Hello and welcome to this very unique course to master Tableau. My name is Baraa and I'm currently leading big data projects at Mercedes-Benz with over a decade of experience in big data, data visualizations, and business intelligence projects. And I'm very excited to be your instructor for this course. In this 21-hour course, I'm going to be sharing everything that I know about one of the most in-demand skill in data science and data visualizations, Tableau. So that by the end of the course, you're going to be able to create amazing dashboards and visualizations in Tableau like I do in the real projects. And I designed this course to take you from zero to hero. So if you are a beginner, don't worry about it. I'm gonna explain everything from the scratch, step by step. So that means this course assumes that you don't have any skills in data visualizations. And as well, all the skills that you're gonna learn in this Tableau course, like data modeling and so on, could be used in any other tools like Power BI and Qlik. And now, of course, you might ask yourself what makes this Tableau course different and unique from all other online courses. This is the only course that breaks down the complex concepts of Tableau into animated visuals, because visuals are very powerful to make complex concepts easy to understand and to follow. And in this Tableau course, we're going to present over 250 animated sketch notes of Tableau concepts. Understanding the concepts and how Tableau work can make you a professional and expert in data visualizations and in Tableau. And in this course, I'm going to provide you with tons of free materials. Like for example, I have prepared 3 different data sources for this course that we're gonna use in all our tasks and examples through the course. And as well, I'm gonna provide you with 3 Tableau cheat sheets. One cheat sheet for all Tableau concepts, another one for all Tableau calculations, and we have one more cheat sheet for all the visuals to help you choosing the right charts. So having those 3 cheat sheets, you don't have to memorize everything. You have a quick reference and access to Tableau concepts. And as well, you have access to all Tableau files and dashboard that is created during the course, and as well all the sketch notes of each section are available to you to download so you can use it later as a reference. So now let's have a sneak peek about the Tableau course. We will start with the basics. What is business intelligence, data visualizations, what is Tableau, and then you're gonna learn the Tableau product suite, and after that we're gonna do deep dive into different Tableau concepts like the Tableau architecture, dimensions, measures, discrete and continuous data. After that we're gonna deep dive in Tableau calculations and functions. You're gonna learn more than 60 different functions in Tableau to manipulate your data. And after that, we're gonna go and cover more than 63 different types of charts in Tableau. And then at the end, we're gonna go and implement Tableau projects similar to the one that I do in real life projects. So now the question is, who is this course for? If you are someone that has never built any data visualizations using tools like Tableau or Power BI, I will be with you in this course in each step, starting from the fundamentals, and we're gonna end up having the advanced topics. And this course is as well for you if you are already a Tableau developer. So I would suggest for you that to take a look to the course curriculum and start at the level that suits you. I have covered a lot of advanced topics and you're gonna have a lot of best practices in this course. And this course is suitable for you if you have experience in any other tools like in Power BI and you would like to pick up a new skill in Tableau. So let's jump in and get started. Now we're gonna have a quick overview of the Tableau course. I have split this course into 15 different sections. For example, we're gonna learn what is business intelligence, what is data visualizations, what is Tableau and the history of Tableau, and why Tableau is a very powerful tool for data visualizations. After that, we're gonna go and deep dive into the Tableau product suite. We don't have in Tableau only one product, we have 8 different products. So I'm gonna go and introduce you to those products, and we're gonna go and compare them side by side for you to understand the differences between them. And I'm gonna help you to choose the right product for your project. Moving on, we're gonna go and deep dive into the Tableau architecture. Here we're gonna learn many different concepts like what is live and extract connections, what are the different types of Tableau files, and then we're gonna deep dive into the Tableau architecture in order for you to understand the main components of the architecture and how Tableau internally works. After all those theory, we're gonna start preparing your environment in order for you to practice with me in this course. So we'll go and download and install Tableau for free, of course, at your PC. We're gonna go and create a free public account. We're gonna download the Training Datasets, and we're gonna publish our first visualization. And at the end, I'm gonna take you on a tour in order to make you familiar with the Tableau interface. And after we have prepared your environment, we're gonna start with the first topic, how to create a data source in Tableau. And here you're gonna gain skills about the data modeling. So we're gonna go through the basics of data modeling and as well how to do modeling in Tableau. And then we're gonna go and learn 4 different methods on how to combine tables in Tableau using joins, union, relationships, and data blending. And of course, we're going to go and compare them side by side for you in order to understand the differences between them and when to use which method. And at the end of this section, we're going to go and create two data sources. Moving on, we're going to start talking about the Tableau metadata. Here, you're going to learn very important concepts in Tableau: the data types, dimensions and measures, discrete and continuous values. Once you understand those concepts, you're going to understand how to create visualizations in Tableau. After this section, we have a small section about renaming. So here we're going to talk about the naming conventions that each developer should know. Then we're going to learn the different techniques on how to rename columns and tables in Tableau. And at the end, we're going to learn how to give aliases to the values. Moving on to the next section, you're going to learn how to organize your data in Tableau. And here we have different methods, like grouping up the dimensions using hierarchies, grouping up the values using groups and clusters. And then after that, we're going to learn sets in Tableau. And at the end, we're going to learn how to create pins in Tableau in order to create histograms. And now in the next section, we're going to learn how to filter our data in Tableau. And here you're going to learn the different types and concepts of filters in Tableau, how to create them and how to customize them. And I'm going to give you 10 tips and tricks about filters in Tableau. And we will learn as well in this section how to sort our data. After that, we're going to learn a very important concept in Tableau, which is the Tableau parameters. Tableau parameters are great in order to add dynamic to your visualizations. So you're going to learn the concepts of parameters, and then you're going to learn different use cases for that, how to make dynamic calculations, dynamic reference line, filters, how to swap measures and dimensions, and to make as well dynamic pins. Moving on to the next section, we're going to learn as well something about dynamic. So we're going to learn the Tableau actions in order to make your dashboards interactive. So as usual, first you're going to understand the concepts of Tableau actions, and then we're going to go through all Tableau actions types. For example, how to go to URL, how to go to sheets, how to filter data using actions, and then how to make highlights using actions, and how to change the values of sets and parameters. And after this section, we're going to have the Tableau calculations. This section is very huge. You're going to learn how to transform and manipulate your data using 4 different Tableau calculations types. So we have the row level calculations, aggregate calculation, table calculation, and the LOD expression. So in this section, you're going to learn more than 60 different Tableau functions in order to manipulate your data. Moving on to the next section, we have another big one. We have the Tableau charts. Here we're going to go and build together more than 63 different charts in Tableau. So we will start with the basic charts like the bar charts, and we're going to end up building very advanced charts in Tableau. And at the end, I'm going to help you to choose the right charts for your requirements. Moving on to the next one, we're going to learn the Tableau dashboards. We're going to go step by step on how to create clean dashboards in Tableau using containers. And now in the last section, we have a Tableau project. Here in this section, we're going to go together and implement a project exactly like I do it in my real life projects. So first, you're going to learn the different phases of each Tableau project. Then we're going to start with the requirements. So you're going to learn how I analyze the requirements of Tableau. And then we start with the implementations of the projects. So we're going to go and build the data sources, the charts, and 2 different dashboards. So with that, you're going to get familiar on how to implement projects in companies using Tableau. So once you go through all those sections, you're going to have a solid knowledge about Tableau.
If you are new to the world of data, you might start hearing a lot of buzzwords from big data to IoT, data science, data engineering, and phrases like data is the new oil. In this tutorial, I will be covering some important buzzwords about the data and what they really mean. So let's dive in. We are living now in the data-driven age, and data is generated everywhere. We people, we generate massive amount of data as we speak. Each click on the internet, each search, email, or even if we are ordering something online, we generate data. We spend hours every day on the social media, liking, commenting, searching. Our smartphone is just all time uploading data about where you are, how fast you are moving, and everything we do online is now stored and tracked as data. Not only our smartphones and computers are connected to the internet and generates data, but also we have something called smart home. We can connect any device at our home to the internet, just put the word smart before it. We have smart mower, smart lighting, smart fitness, voice devices, security systems. All those devices could be connected to the internet and start generating massive amount of data. And this is what we call Internet of Things, IoT. IoT is the concept of connecting any device, anything, to the internet in order to generate and exchange data. Not only we have IoT at our home, but also everywhere. We are living in the digital transformation. In the industry and manufacturing, you might heard of the concept Industry 4.0, the first industrial revolution introduced in Germany. It's all about smart factories connecting machines and devices to the internet in order to exchange data. And now we can find IoTs in the cities. We are trying to implement those smart cities where we're gonna connect everything in order to reduce waste, saving money, improving quality. We have as well IoTs in our cars. Our cars are loaded with sensors and devices that are connected to exchange data for many reasons, like driver assistance, object recognitions, self-driving systems. The list is just so long. In 2022, we have around 14 billions of physical devices, things from small household cooking devices to the sophisticated industrial machines that are connected to the internet, generating and exchanging data. The amount of generated data every day from IoTs, social media, websites, machines is truly mind-blowing. There are currently over 44 zettabytes of data in the entire digital universe. That is 21 zeros. So that means we are no longer dealing with normal, traditional data. We are dealing now with the big data. So what big data means? There is 3 indicators that help us to understand whether our data is big, and they are defined by the 3 V's. The first V is volume. Well, big data is big. With the growth of the internet, mobile devices, social media, IoTs, the amount of generated data from those sources has grown dramatically. The second V is velocity. In normal data processing, we used to process slow data, or we call it batch data, once a day or something, and then we store it in the disk. But in big data worlds, the sources are generating streams of data with very high speeds. That means we have to process and analyze the data in real-time fashion, and then we store it in memory instead of disk. And the third V is variety. In traditional systems, most data types could be captured in raw, unstructured tables like database or Excels, but in the big data worlds, data often comes in semi-structured format, for example, server logs in XML or websites, or the data comes in unstructured format like videos, audios, images, free text. So in big data, we have not only to deal with structured data, but also with semi-structured and unstructured data. So the big data terms means how we can efficiently store, process and analyze our data when it has huge volume, high speed and different types in order to reveal significant values for the business. But we still have a problem with that all those generated data are raw data. Raw data are just unprocessed rows and rows of numbers that are really hard to understand, hard to read, badly structured, and almost has no value to the business. Almost 70% of the world's data are unused. Raw data, if left without processing and refining, is just worthless. Waste of money, waste of space, and it generates digital waste stored in very expensive data centers. And that's why we have the very famous phrase of the famous British mathematician Clive Humby, data is the new oil. Well, it means that we have to extract the raw data like we are extracting oil, we have to refine it, process it, transform it into something useful and has value to the business. Well, what this really means is that most of the companies are sitting on a very big field of a new oil, raw data, and most of them understood that data is their most valuable asset. They have to extract it, they have to analyze it in order to reveal insights that could help them in order to make faster and better decisions. And that's why most of the companies are hiring army of data workers, as we know the demand for data scientists is increasing rapidly and the supply is low. So now what we can do with all those chaos, all those generated unprocessed raw data? Well, we can do the following stuff. So what we can do, we can design or build a data architecture. Data architecture is the process of creating a blueprint on how we organize, process, and store our data into different layers for different purposes. So data architecture makes it easier to manage, protect, and access our data. Another thing that we can do with the raw data is data engineering. Data engineering is a very complex process of designing and building data pipelines and data storages. In data engineering, we usually build ETL processes to extract the raw data from multiple sources, then transform it and then load it to the target storage in order to make it highly available and usable for the data scientist or any other end user. Another thing that we can do is data modeling. So data modeling is the process of connecting the dots. So what we're going to do is we're going to put all the data into entities and objects. Then we describe the relationship between those entities in order to help us and help the programs to understand how the data are related to each other. Another thing that we can do with the raw data is we can do data mining. Data mining is the process of analyzing massive amount of raw data in order to discover knowledge, to discover business intelligence like patterns and trends, to solve problems and to mitigate risks. Another use of the raw data is that we can use it in machine learning. In machine learning, we are providing the computers with two things. First, the raw and historical data, together with the mathematical models and algorithms. So once the computer has those two things, it's gonna start training and practicing in order to perform tasks like predictions. So it's like human, the more the machine practice and train, the better and accurate the result's gonna be. And next we can do data science. Data science is the scientific study of data, and it combines three major powers. The power of programming languages, together with the mathematics and statistics, and the knowledge of specific domain, in order to uncover valuable knowledge and insights from our raw data. One more thing that we can use on the raw data, and my favorite one, is that we can use data visualizations. So data visualizations is the process of converting numbers and raw data, which is normally hard to understand and to read, into visuals and charts like bars, pie, tree, plots, in order to make it easier to understand and easier to read, which really helps in the decision making. There are many other things and processes that we can apply it on the raw data, but these are the major fields of work that we can use in order to convert the useless raw data into knowledge that has significant impact and value to the business. Alright, let me tell you this story. We have shops in 3 different cities in Germany. In Stuttgart we have shop, Berlin and Hamburg. And our 3 shops are generating every business day a lot of raw data on sales, inventory levels, products, staff, costs and so on. And now we have a group of people that are the decision makers, like managers, HR, finance, and they have many questions and decisions to make. So they might have questions, for example, what happened? And another questions about what will happen. Now, if the managers try to find the answers from the raw data, they might find nothing and no answers, because the raw data are usually very complex and badly structured, and they are really hard to understand. And that's why they're gonna go and hire some data analysts, for example, in order to help them finding the answers from the raw data. So the data analyst is gonna go and start analyzing the raw data by doing some magic, for example, cleaning up the data, connecting objects together, and aggregating the data in different levels, and at the end the result will be communicated as, for example, spreadsheet to the decision makers. And in the other hand, the managers can hire data scientists in order to help them finding answers about what's gonna happen or uncover unknown facts and insights. So the data science gonna as well go and start analyzing the raw data, but this time using different methods, like for example data mining, machine learning, or train a model, in order to find new insights, new knowledge, and answers to the questions. At the end, the output gonna be communicated as well to the managers as numbers and spreadsheets. Now, both of the data scientists and the data analysts did an amazing job working on the raw data and analyzing those stuff. But the problem here is that the output might be hard to understand and to read, because those managers are usually people that don't work directly with the data every day, so this could lead to a big gap between those managers and the results. And now, in order to bridge this gap and make everything easier, we can use the power of data visualizations, and the result presented from the data scientist and the data analyst should be converted from these boring numbers and spreadsheets to visuals, graphs, and charts. The visual representations of the data will just do the magic by making everything clear and easy. And it's gonna bring very easily the wow effect once you are presenting your results. So it's gonna help the managers to immediately find their answers, and they're gonna start making decisions using the data. This process, we call it a business intelligence, or as a shortcut, BI. So now the question is why visualizations is so powerful. With the simple visual communications, you can make a huge difference. Since the start of the humanity thousands of years ago, an early human used visuals in order to tell a story. And until now in the modern age, the human still uses visuals in order to tell any story. Because we humans, we are visual creatures. We think in pictures and in visuals. If we see a tree, our brain gonna store it as a visual, as an image in our brain. Studies say that 90% of the information transmitted to our brain is visual. But if we read the word tree, our brain has first to transform it to a visual before storing it, which is way slower. In fact, the human brain processes visuals 60,000 times faster than a text. More facts about our brain is that we remember most of what we see and interact with. It's proven that the human remember only 10% of things we hear and 20% about what we read, and it's also proven that we remember about 80% of what we see and interact with. That's why we have the famous phrases of "a picture is worth 1,000 words" and "seeing is believing." Having all those facts, no wonder that in digital channels, the visual content is taking over. Posts, tweets, articles, news, presentations, dashboards, you can find visuals everywhere. So now the question is, what is data visualizations, or sometimes we call it data viz. Data visualizations is the process of converting boring numbers and raw data into interesting graphical elements like bars, pie, tree, plots, and so on. So data visualizations brings the data to life, makes you the master of storytelling of the insights hidden within your numbers. So it's like an art of converting highly complex, massive amount of data sets into something very simple, something very easy to understand and to interact with. Imagine yourself to be one of the managers and you have two data analysts. One of them is presenting the result in spreadsheet filled with numbers, and the other data analyst is presenting the result with visuals filled with graphical presentations of the data. And both are presenting the same facts. Which report you will prefer? I would go with the right one because the left one is just dry numbers, boring, and unlikely you will be able to spot any trends and patterns. So the main benefit of data visualizations is telling a story, which arms you with tools in order to make the right decision at the right time. There are many other benefits like seeing the big picture, tracking trends, making smarter and faster decisions, discovering unknown facts, patterns, trends, and getting as well more engagement from the end users by asking more and better questions. Alright, so with that we have learned what is data visualizations and why it is very powerful and important. And next we will compare Excel to BI tools like Tableau and why you need to use Tableau instead of Excel. Over and over again, I'm asked the same question, why I should bother learning and using Tableau or Power BI for data visualizations if we have Excel. In this video, I'm going to explain for you my 6 reasons why we should use a modern BI tool like Tableau and Power BI and not use Excel for data visualizations. And we start right now. There is around 1 billion users globally are using Microsoft Excel. I worked in many companies and I can tell you, people are just addicted to Excel. They love it. They use it for everything, as planning tool, data entry, data analysis, and data visualizations. But the main problem here is that the more a company grows, the more it generates data, and because everyone is familiar with Excels, they're gonna keep using them in big data use cases, and they're gonna face really hard time managing those spreadsheets and dealing with the limitations in Excel. In these situations, it's really time to switch to a modern BI tool or data visualizations tool like Tableau or Power BI. Now let me show you how BI is done with Excel. We usually have different source systems and a data analyst that's gonna go and start exporting manually the data from those systems and import them in Excel. And then some calculations gonna be done, and at the end a report will be generated. The Excel files then will be accessed from different business users. In the other hand, we can do BI with a modern tool like Tableau. So what we're gonna do, we're gonna connect Tableau directly to those source systems, and the data analyst gonna start developing a report or dashboards in Tableau. And at the end, the business users will access Tableau in order to see those dashboards. So far, you can say, okay, both look really similar. So now let's dive in order to show you what is the real benefit of having a modern BI tool like Tableau or Power BI, and the limitations that we have in spreadsheets like Excel. The first benefit is automation. If you are using Excel and we made some nice reports, it's time now to update the data. And how we do that in Excel? We update data manually. So some employees have to sit down every day and go through the process of extracting data from those source systems, importing them in Excel, do calculations, and at the end prepare the reports over and over again, which is very time consuming. But if you are working with a modern BI tool like Tableau, we can automate this boring task by creating schedule to refresh the data. For example, we can create a schedule in Tableau every day at 7 o'clock morning. Tableau should automatically connect to the data sources, pulls the data, and prepare the reports. There is two benefits of doing that. First, we eliminate the human errors, which is very common thing in Excel, and sometimes those mistakes can lead to wrong decisions and to finance loss. And the second benefit, of course, we no longer need employees that is dedicated only for this boring task of exporting and importing data manually to Excel. Another benefit here is the capacity. If you are working with Excel and one of our source systems start producing and generating massive amount of data, here we have problem in Excel because we can handle around only 1 million records. So our Excel file gonna breaks and we're gonna start getting error messages like the data set is too large. So what we usually do in Excel, we're gonna go and start splitting the main file into small multiple files in order to manage the huge volumes of data, which is really hard to manage. In the other hand, if you are working with Tableau, we don't have to worry about all those stuff. We have no problem in Tableau because Tableau is made for big data use cases and can very easily handle massive amount of data. So we might just change the connection type from extract to live in order to handle it. Another benefit is security. If you are working with Excel, it's really hard to hack into Excel. Even if you are using password protected spreadsheets, it still can easily hacked nowadays. And the users are really used to share their Excels in emails, copy it to USB or store it locally at their computers, which is not secure at all. So all those stuffs could cost the companies a lot if sensitive and confidential data is accessed by competitors. But if you are working with modern BI tool like Tableau, it's gonna provide us with superior security features like advanced access control, data security, network security, and plus if you are working with Tableau, we don't have to export the data. We can just share the dashboards and reports between employees, and only if we grant them access rights, they can see the data. Another benefit is the role level security. In many companies, they have a lot of confidential sources, and they start to understand how important it is to apply the principle need to know. The principles needs to know says, a user shall only have access to the information that their job functions requires. That means we cannot go and share all data to all users. We have to have some data restrictions. For example, a sales employee should not see all data like manager, and finance employee should not see all personal information like HR, and so on. That means if you are working with Excel, we have here again to split the main files into specific reports for specific rule. But in the other hand, most of the modern BI tools, they offer a feature called Row Level Security, RLS. Row level security refers to restricting the rows of data a certain users can see based on the policies that we define. Using this technique gonna enforce the need to know principle and gonna make our life easier by just having one dashboard accessed by different types of users, and then based on the rule, they're gonna see the data and the informations that their job requires. Another benefit is reducing chaos. Let me tell you how we usually work with Excel. A data science will start exporting data from one source system, and he's gonna make a report called version 1 report. And then for other requirements, he's gonna make a version 2 report. And eventually we're gonna have a final report. And we have another data analyst working in different source system, and the same thing gonna keep happening a few times back and forth, and eventually we're gonna end up having different 6 versions of the reports. And if we scale this impact, you will notice that you are slowly poisoning your business, and the end user is gonna have to access different versions of the reports. And now if we ask how old is the data in our reports, we will get different answers. One version gonna be 10 days ago, another one 8, 4 and 3 days. That's mean we don't have single point of truth for our data, and that's why having modern BI tools gonna help us to eliminate such a chaos and gonna help us building a single point of truth for our data. One last benefit that I would like to talk about is visuals. Although Excel offers visualizations, but it is sometimes very limited when we are producing complex visuals. In Excel as well, creating visualizations is very time consuming, including a lot of manual steps, and as well those visuals gonna be static and not interactive. But in the other hand, if we are using Tableau, everything gonna be automated and super fast. We can create new reports and views very quickly by just drag and drop, and they offer way more interactive and cooler visuals than Excel. Alright, the main reasons why I prefer working with modern BI tools like Tableau and Power BI and not Excel for data analysis and data visualizations are automations, security, big data use cases, and interactive visuals. It's not about Excel versus Tableau, it's all about using the right tool for the right use cases and not to misuse a tool. Excel is a great tool that is used by billions of people because it's very easy to use, cheap, professional spreadsheet for data entry and complex calculations, but when it comes to data analysis and data visualizations, we have way better tools than Excel like Power BI and Tableau. And you can still use them together. For example, you can do your complex calculations in Excel, and the final result can be imported in Tableau in order to do better visualizations and to get more insight about the results. The thing is, the world is changing very fast and the companies are generating massive amount of data. So instead of using traditional spreadsheets like Excel, we have to use more powerful tools in business intelligence to help us quickly find insights, trends, patterns in order to make faster and better decisions. So now the question is, what are the best tools for data visualizations? A leading research company called Gartner publishes every year the Gartner Magic Quadrants to show who are the leading product in specific domain. And if you check the Magic Quadrants for analytics and business intelligence platforms, for the last 10 years, you can almost see always the same leaders. We have Tableau, Power BI, and ClickView. Since 2012, and I'm working with a lot of data visualizations tools, and I can say that although 3 tools are really great tools, they have their advantages and disadvantages, but by just checking the data visualizations aspects, I can say that Tableau is here a winner, because data visualizations in Tableau is a core concept and really the best tool for data scientists and for big data. Alright. The first question is, what is Tableau? A quick answer could be, Tableau helps us to convert this to this without any technical or programming skills. So Tableau converts complex and boring raw numbers into beautiful visuals and charts, which is really easy to understand. And the key features in Tableau is interactivity, easy to build and to use, and fast performance. We can call Tableau with many names like a data visualization tool, a business intelligence or BI tool, or sometimes we call it a reporting tool. Well, Tableau is all of them, but I choose to call Tableau a data visualization tool because data visualizations is the core concept of Tableau. Now let's have a quick history about Tableau. In 2003, Tableau was founded by 3 guys, Pat, Christian, and Chris, as a result of computer science project at Stanford University. They focused on visualizations technique to analyze data inside databases. And then in 2019, Tableau was acquired by Salesforce in a deal worth over $15 billion. And for the last 10 years, Tableau was named as a leader in Gartner Magic Quadrants for business intelligence. Tableau has a clear mission to help people to see and understand their data. They really focus on keeping Tableau intuitive and easy to use. That's why Tableau does not require any technical or programming skills in order to build amazing dashboards and insights. That means the target audience of Tableau is not only for technical users like IT, data analysts, data scientists, but also for all other non-technical users like a business user, an end user, a teacher, and so on. This aspect is a game changer of changing the old mindset of having only IT and technical people working with data and building visualizations, but now we have modern data visualizations tools like Tableau, which opens the door for everybody to start working with data. That's why tools like Tableau helps organizations to be data-driven. And now Tableau is widely used. You can find Tableau almost in all organizations, industries, sectors, in all departments, because most of those organizations want to empower their employees with tools like Tableau in order to make better, faster, and smarter decisions using data. All right. Tableau is not the only leader in business intelligence and data visualization market. There are many other tools that are available like Power BI, ClickView, and so on. But now if you ask me what makes Tableau so special, why Tableau is so widely used, I would give you 4 reasons. The first reason is performance. The sources now are generating massive amount of data, and Tableau is designed and optimized to handle huge volumes of data without impacting the performance in the dashboards. And that's because Tableau is using high performance in-memory data engine to help analyze large data sets, where the data gonna be stored inside columns instead of rows, which gonna boost the performance in dashboards. Tableau has no limitations or whatever to the number of data points in the visualization. For example, on this view, we have over 1 million data points without any problem. This allows us to analyze large data sets in order to find trends, patterns with great performance. And all other tools still enforce row size data point limitations, which is not really helpful for data analysis. The second reason is quick and interactive visualizations. Compared to the other tools, with Tableau we can create rich and beautiful visualizations in just few seconds. I'm gonna show you now a quick example how to cluster my data and how to calculate the forecast. In order to do such a complex job in Tableau, we will just use drag and drop. So let's see how simple it is. Alright, so we're gonna go to the orders, take the sales, put it in the columns, profit in the rows, and take the order IDs in the details. And I want to see all my members over here. And now we go to the analytics pane and then double click on the clusters. So with that, I have very nice 4 clusters of my data. The next step, I will create a forecast of my data. So I'm gonna take the order ID, put it in the columns, and then we're gonna take the sales. I would like to change the visual to bars. So I have now here around 5 years. What we're gonna do, we're gonna go to analytics and just click on the forecast. And that's it. So I have a forecast of 2 years of my sales. And now I'm just gonna go and put them together in one dashboard. So I'm gonna create a new dashboard, drag and drop the clusters, drag and drop the forecasts. I'm gonna link them together with the filter. And that's it. So now we have both of them. And if I click around, I will have an interactive dashboard for the forecast and for the clusters. The third reason, Tableau is user-friendly. As you can see, we have done very complex analysis with just drag and drop without writing any code, and this is exactly what Tableau wants. It's very intuitive and user-friendly, and this is the major strengths of Tableau. It just opens the door for all non-technical users to have a chance to work and play with data to solve their daily problems without the need of IT. But in the other hand, Tableau is integrated with programming languages like Python and R, which opens another door for advanced data visualizations, which might be used from data scientists. And the last reason is community. If you are working with Tableau, well, you are not alone. You have a huge Tableau community. In the community, we have around 2 million students and teachers, and in Tableau Public, we have around 5 million data visualizations that are published. and there's around 200,000 questions and ideas that are shared in Tableau forums. Having such a huge community is a big plus for any tool. It's very important because while you are working with data, you might face some problems or you have questions. It's very important that you have a place where you can go and ask your questions and get advices from other developers all over the world. And not only that, you can as well get inspired from the shared visualizations from other developers. You can find the important links about the Tableau community in the video description below. Alright, so my 4 reasons why Tableau is one of the best tools for data visualizations are: Tableau can handle massive amount of data, very suitable for big data use cases. It offers beautiful, quick, interactive visualizations. Tableau is intuitive and user-friendly, no coding or technical skills are required. And the last reason, Tableau community is very huge. One more thing that I would like to add is that data visualizations is really one skill that you have to master as a data scientist or data analyst. And Tableau is an amazing tool for data visualizations. That's why I highly recommend to learn or to get familiar with Tableau. It's gonna be like a huge advantage for your career. Alright guys, so with that you know my reasons why I think Tableau is a leader in data visualization. And with that, we have finished the first chapter of Tableau, where we have covered a lot of important terms of data and Tableau. And in the next chapter, we will have an overview of the Tableau product suite, where I will introduce you to 8 different Tableau products. Tableau products. In Tableau we have 8 different products, and it's really important to understand them and understand the differences between them. So that's why I'm gonna go and give you a quick overview of all 8 Tableau products, and then we're gonna go and compare them side by side in order to understand the differences between them. And at the end you're gonna learn the decision-making process that I usually follow to choose the right product for your requirements. So now let's start with the first topic, where we're gonna have an overview of the development process and products. So now let's go. Alright, if you think Tableau is only one software, then you are wrong. If you visit the homepage of Tableau, tableau.com, you will find many different Tableau products like Tableau Desktop, Public, Server, Cloud, Prep, Reader. I can say at the start, it might be confusing having all those Tableau products, but don't worry about it, I'm gonna explain them one by one, so you can choose the right combinations of Tableau products for you or for your organizations. It's really important to understand the differences between them, the functionalities and the limitations of each Tableau product. And let's dive in. So Tableau product suite contains 8 different products. We have Tableau Desktop, Tableau Public Desktop, Prep, Server, Cloud, Public Cloud, Reader, and Tableau Mobile. Alright, the first thing to understand is that we can split those products into 2 main categories: developer tools and sharing tools. Tableau Developers Tools, as the name implies, they are tools that's going to help you to build data visualizations by creating and designing dashboards, charts, reports, or to do data preparations or data engineering by preparing the data for data analysis. Under this category, we can find 3 Tableau products: Tableau Desktop, Public Desktop, and Tableau Prep. And now in the other category, we have the sharing tools. Those tools can help you to share and collaborate your work that you have done and created using the developer tools. Under this category, we can find 5 Tableau products: Tableau Server, Tableau Cloud, Public Cloud, Reader, and Tableau Mobile. Alright, so now first let's focus on the Tableau products under the category developer tools. And now we can go and as well split the developers tools into 2 groups based on their purposes. We have data visualizations and data engineering. Underneath data visualizations, we find 2 Tableau products: Tableau Desktop and Tableau Public Desktop. And underneath data engineering, we have only 1 Tableau product, and that's Tableau Prep. Alright, so now after we understood the main categories and the main purposes of Tableau products, we will go now and talk about the development process in Tableau. Alright, so basically we have 3 very simple steps in the development process in Tableau. The first step, we connect our data to Tableau. Then in the next step, we start building our data visualizations to do data analysis by creating report, chart, and dashboards. And in the third step, we share our work by publishing it. The 2 products to do these 3 steps are Tableau Desktop and Tableau Public Desktop. In many cases, the quality of our data is bad and not ready for analysis. That's why we add one more pre-processing step to
to prepare our data before we start building our visuals, and we can use for this step the product Tableau Prep. Alright, so now let's do deep dives into Tableau developers products one by one in order to understand the key features and as well the limitations for each one of them. Tableau Desktop is a software you download and install at your PC. With Tableau Desktop, you can connect to many different source types. There are over 90 data connectors. You can connect to Tableau server or to connect to files like Excel, text, JSON, or to on-prem servers like MySQL and Oracle, or to cloud like Amazon, Google, and Microsoft Azure. Once you connect Tableau to your data, you can start building your data visualizations. In Tableau Desktop, you will find many tools and functions to help you creating charts, reports with just drag and drop. And then you can combine those different reports into interactive dashboards. And after you're done building your views and dashboards, then you have three options to share your data by either publishing them to Tableau server, Tableau cloud, or to Tableau public cloud. Or even you can store your workbooks locally at your PC. Alright, so Tableau Desktop is the backbone product of Tableau. As Tableau developer, you're gonna spend 90% of your time using this tool. Tableau Desktop is a developer tool to build data visualizations where you connect your data, build dashboards, and then publish them. Sadly, Tableau Desktop is not a free tool like Power BI Desktop. In order to work with Tableau Desktop, you have to buy a license. I think they offer some kind of trial phase, or if you are a student, you get like 1 free year. Don't take my words, it's better to check the current offering from Tableau in their homepage. With Tableau Desktop, you can connect over 90 different data sources. You can publish as well your work everywhere to Tableau server, Tableau cloud, and Tableau public. And since Tableau Desktop requires a license, you don't have any limitations or whatever on how many rows and data you can store and process. Tableau Desktop is meant for data analysts, data scientists, BI developers who work professionally in companies in data analytical projects. Alright, so that was a quick overview of the Tableau Desktop. Next, we will check the Tableau Public Desktop. So Tableau Public is the free version of Tableau Desktop. It is very similar to it. It's a developer tool in order to build and publish data visualizations, and since it's free and requires no license, it comes with few limitations. In Tableau Public, we have around 10 data connectors. You can connect only to local files at your PC. Another limitation is that you can store and process only 15 million rows of your data, and you can publish only to Tableau Public Cloud. So that means you cannot publish your work in Tableau Server or Tableau Private Cloud. And the last limitation is that you cannot store your workbooks at your local PC. But here I have to be fair that the most important part is that all functions and tools in order to build visuals and dashboards are completely available in Tableau Public, like in Tableau Desktop, which makes really Tableau Public as a great alternative and tool for beginners in order to practice and to learn Tableau before they go and buy licenses. And to be honest, that's why I decided to go with Tableau Public in all my tutorials, so that anyone can follow and practice with me without having you buying any licenses. Tableau Prep Builder is a software you download and install at your PC, and you can use it to prepare your data before you start analyzing it. Same as Tableau Desktop, you can connect to many different source types. There are over 90 data connectors like Tableau Server, Files, On-Prem, Cloud, and so on. Once you connect Tableau to your data, you can start building data flows where you have access to tools and functions to help you to transform your data. For example, combining data, cleaning, filtering, aggregating, and all other art of data engineering tasks to prepare your data for data visualizations. And at the end of your data flow, you can store the new prepared data in 3 different places, either as a file at your local PC or publish it as a data source in Tableau Server or Cloud. And the last option, you can write the output directly in databases. And after you are done building the data flows, then you can publish them in Tableau Server or Tableau Online for automations. And in Tableau Prep, you have the option to store your data flows locally at your PC. Alright, so Tableau Prep is a data engineering tool to prepare our data to get ready for analysis. Sometimes the data that we are connecting to Tableau Desktop has bad quality and we cannot use it immediately in our dashboard. That's why we spend like hours and hours of cleaning up, organizing, combining, preparing our data, and that could be really time consuming. So for this situation, we could use Tableau Prep to help us with this process. So Tableau Prep is a developer tool for data engineering where we connect to our data, build data flows, and then publish them. And it's not a free tool, it requires a license. In Tableau Prep, we have over 90 different data connectors. The output of the data flows could be stored locally at your PC or as a Tableau data source or directly in the databases, and we can publish the data flow either to Tableau server or to Tableau cloud. Tableau Prep is not like Tableau desktop. We don't have any free version of Tableau Prep, so there is no Tableau public prep. Alright, so now let's go and have a summary of the three products where we're gonna compare them side by side. The main purpose of Tableau Desktop and Public is to generate data visualizations, but the main task of Tableau Prep is for data engineering. Now, if you are talking about the costs, both Desktop and Prep requires licenses, but Tableau Public is free to use. And now about the security aspect of the data, Tableau Desktop and Prep are secure since you can publish them to private servers. But Tableau Public, you have to publish your work to public platforms where everyone can see your data. So you cannot secure your data in Tableau Public. And the next point, data limits. Since Public is free, it comes with the limitations of 15 million rows. But Desktop and Prep, you will get no limitations. The next point is connectors. In both Desktop and Prep, you have over 90 different data connectors like files, API, servers, cloud, and so on, where in Tableau Public you can connect only to files. And if we talk about the live connections aspect, the only tool offers a live connections to your data sources is Tableau Desktop. You cannot make live connections in Tableau Public and in Tableau Prep. You have always to work with extracted data. The next point is about storing your files locally. Both Tableau Desktop and Prep allows you to do that by storing your work locally at your PC. But in Tableau Public, you cannot do that. Instead, you have always to publish your work to Tableau Public Cloud. The last aspect is about the target audience. Tableau Desktop is made for data scientists and data analysts, but Tableau Public is made for anybody who wants to work with data visualizations. And Tableau Prep is made for data engineers. Alright, so now with this we have good overview of the three Tableau products for development, and now comes the question when to use which product. So now let me guide you in my decision-making process using the following flowchart. First, we ask the question for which purpose. If we need a product for data engineering, then it's easy. We have only one Tableau product, and that is Tableau Prep. Now, if we need a product for data visualizations, then we can ask more questions. The next question, do we need to connect to server, API, databases, or to cloud? If the answer is yes, then we have to use Tableau Desktop. And if the answer is no, then we ask the next question, can our data be public? If the answer is no, our data is confidential, then we have to use Tableau Desktop. But if the answer is yes, our data can be public, then we jump to the next question. Do our data sources contain more than 15 million rows? If yes, then we have to choose Tableau Desktop. But if the answer is no, our data sources have less than 15 million rows, then we jump to the last question. Do we need to have live connections to our data sources? If the answer is yes, then we have again to choose Tableau Desktop. But if the answer is no, then finally we can go and use Tableau Public. Alright, so if you follow those questions and this chart, you can easily decide when to use which Tableau product. Alright guys, so in the previous tutorial we split the Tableau products into two main categories, developers tools and sharing tools. Now we're gonna focus on the second category, the sharing tools, where we have Tableau Server, Cloud, Public Cloud, Reader, and Tableau Mobile. And as the name implies, those products can help us to share our reports and dashboards with others. And in the last tutorial, we have talked about the 4 steps of Tableau development process. Now we're gonna do deep dive in the step number 4, where we're gonna talk about the different options that we have in order to share our reports and dashboards with others. If you want to share your visuals with your colleagues in your organization, then we have here few options. First, you can install Tableau Server product on servers using the infrastructure of your organization, and then you can start publishing and sharing your dashboard there. Then your colleagues can either use their web browser or they can use Tableau mobile app on their smartphone or tablets to view and interact with your dashboards directly from the server. The second option we can install Tableau Server product on cloud cloud service providers like Amazon AWS, Microsoft Azure, or Google Cloud. And then you can publish your dashboard there, and the same thing here, users can use web browsers or Tableau Mobile in order to access your work. The third option we have, you can use Tableau Private Cloud Service. Here you don't have to install any Tableau server or anything. You will get everything prepared from Tableau team. You can start immediately publishing your dashboard there, and your users can consume it from Tableau Cloud. And now let's say you want to share your dashboards with everyone in the world and make it public, then you can use Tableau Public Cloud. You don't have to install anything, you can immediately publish your dashboard there, and users all around the world can use their web browser to access your dashboards and data, but they cannot use mobile app in order to access Tableau Public. And now to the last option that I really don't like to use. If you want to share your reports to individual users, you can send them a Tableau file with the format TWBX, Tableau Packaged Workbook, which contains your data plus your reports and dashboards. And then the users can view this file using Tableau Reader software installed at their PC. Alright everyone, so now in order to understand the real differences between Tableau Server and Tableau Cloud, we have to understand the back-end details and some basic concepts about hosting servers. Let's go. Let's say we are a startup company and we want to host our own Tableau application and build the entire infrastructure for that reason. There is a long list of tasks that should be done. Of course, the first thing that we need to do is to go and buy some hardwares and configure them, like servers that will run the applications. And each servers need as well storage, so we have to provide additionally storage infrastructure like some hard disk driver and SSDs. Servers needs to be as well connected to the internet, therefore we have to provide as well all the networking infrastructure. Once we have all those stuffs, then we have all hardwares needed. The next thing that we need to do is that we're gonna go and start installing and configuring some softwares. Like we're gonna install an operating system, for example Windows or Linux, and many other middlewares. Once the operating system is in place, then we have to install and configure Tableau Server application. Once we have all software and hardware ready and running, it's finally now the time to set up our Tableau project, and we have to manage the following tasks. We have to start adding users to the Tableau server and map them to the correct licenses. We have as well to create schedules and tasks to refresh our data inside Tableau server, and then we have to start monitoring the Tableau jobs. Alright, so now we come to the big question that we have to answer. Who will manage what? The first option you have, if you decide to manage all these layers, that means we are talking about the on-premises model. So it's clear ownership. You manage everything from top to bottom. Hardware, the software, and the project itself. But now if you say, you know what, this is too much to manage. We don't have the money to buy all those stuff and hardwares at the start, and we don't have the time to take care of them and maintain them. Then you will start thinking about outsourcing the hardwares, where you're gonna buy a service from cloud providers like Microsoft Azure, Amazon AWS, or Google Cloud, so that they manage the hardware and you manage both software and projects. And this is what we call Infrastructure as a Service, IaaS, the first letter of each word. But now if you say, you know what, our IT team is very small, we don't even have the time to keep those softwares updated. Each time Tableau makes a new release, we have to install a new version of Tableau server, which is really wasting our time, and we are not able to focus on our core business project. We don't have the resources to manage our own software. Then you start thinking about outsourcing the software layer. To do that, you can buy a service from Tableau. It's called Tableau Cloud, where Tableau team gonna manage everything for you, both hardwares and softwares. And this is what we call Software as a Service, SaaS. Okay guys, so now let's summarize and compare the three hosting options. The first point is about hosting setup. On premises, you need Tableau server installed in your organization servers. In IaaS, you need as well Tableau server installed in cloud service provider, for example Microsoft Azure. And in SaaS, you just buy Tableau Cloud product. And now for the question, who manage what? In on-premises, you manage everything, the hardware, software, and your project. And there is no outsourcing. In IaaS, you manage both software and your project, and the cloud service provider gonna manage only the hardware. In SaaS, you manage only your business projects, and Tableau gonna manage both hardware and software. So now let's check the advantages and disadvantages of each service model. For the on-premises, the good thing here is that you have full control of everything, the hardware and the software, and your data remains behind your firewalls. This is very important if you have critical or sensitive information that should not store outside of the company's firewall. But the drawbacks here, you need a dedicated hardware and software administrators to deal with the maintenance, patching, and many other tasks. It is very costly at the start of the project. You have to pay a lot for the hardwares and the softwares, and it's not flexible. It's really hard to scale up or scale down your hardwares as needed. Having all those stuff, generally you have less time for your business project. Alright, so now let's move to the IaaS. The first advantage, it gives you flexibility. You can scale up, scale down the hardwares as the business needs, and there is no upfront cost for buying hardwares. But the downside of IaaS is that you still need administrators to manage your softwares, to do installations, patchings of your softwares, and if you don't pay attention for the cost, you might end up paying big bills. Now let's move to SaaS. The main advantage in SaaS is that it allows your IT team to focus only on the core business projects and allows you to implement projects in very short time. And the other good thing is that your software will be always up to date. Tableau team gonna deal with that. But the downside of SaaS is loss of control. You will be at the mercy of Tableau team. If anything bad happen, like security problems, all your organization's data might be compromised. And the other disadvantage is that you might have bad performance or networking issues connecting Tableau to your source systems. And my advice here is that you should avoid reinventing the wheel. Always take advantage of services that do things not part of your core business. Every hour you spend patching an OS or installing updates for your software or replacing hardwares is an hour not spent enhancing and refining your dashboards in Tableau. Alright everyone, so now we're gonna do deep dives into Tableau sharing products one by one in order to understand their key features and as well their limitations for each one of them, and we start with Tableau Server and Tableau Cloud. As Tableau developers in organizations, we need to share our reports and dashboards with the other colleagues in our organization. So we need to put those dashboards in a trusted environment or platform in our organizations, and we usually have 4 requirements. The first requirement, it should be safe and secure. We want to control who is accessing our data and dashboard. Second, it should be easy to scale. Third, it should be robust, that can handle a huge amount of users and data. And the last requirement, it should be powerful and deliver high performance. No one wants slow dashboards and reports. And now in order to build this trusted environment with these requirements, we have 2 Tableau products, Tableau Server and Tableau Cloud, and we have 3 hosting options, on-premises, IaaS, and SaaS. Don't worry about the terms, I'm gonna explain them. Tableau Server and Cloud, they are very similar at the user interface level. You will not notice any differences, but if we are checking the backend level, there is a big differences between them. So now first, let's talk about the user interface level of Tableau Server and Tableau Cloud. Once you publish your dashboard to Tableau Server or Cloud, you can share them by providing links to the users across all departments in your organization. And then the users, they can access your dashboard using their web browser without installing any software at their end. And if you give them access, they can start exploring your data. In Tableau Server or Cloud, you can manage your users by adding and removing them. Give them specific rules like admin, creators, viewers, or explorer. You can manage your users as well by adding them to groups. Another important task you can do in Tableau Server or Cloud is that you can automate your tasks. For example, you can create a refresh schedule to refresh your data sources on a regular basis, like once a day. In Tableau Server and Cloud, you can monitor the tasks and schedules to check the status. if the job failed or succeeded. And you can find many other statistics about the runtime, the average queue, and error messages, and so on. Not only the users can view the dashboards in Tableau server or cloud, but also they can create a new one. If you give the users enough rights, they can even start creating their own insights and views directly on their web browser without having them to install any Tableau desktop. It's something we call self-service BI. Alright everybody, so now with this we have clear picture about Tableau server and Tableau cloud. So now let's talk about the other sharing Tableau products. Tableau Public Cloud is a free cloud service managed by Tableau team. Everyone in the world can share visualizations in this platform. So if you publish your dashboards in Tableau Public, everyone can access it, interact with it, and even download it. Tableau Public is like social media. You can edit your profile and add your personal informations. In Tableau Public, you have a huge gallery of vizes built by people all around the world. It hosts currently over 5 million visualizations. In Tableau Public, if you are browsing and you found some interesting dashboard like this amazing dashboard from Aliases, you can add it to your favorites, and then you can check what other vizes did Aliases created and published to public. And like any other social media, if you like her content, you can go and follow her to see her new updates. And if you are inspired of one of her dashboards, you can go and install the whole workbook to see how she did build these amazing dashboards and see all details. With that, you are expanding the knowledge in Tableau development. So using Tableau Public, you can get inspired from others and you can get connected to other Tableau developers from all around the world. And one more cool thing about Tableau Public, if you are searching for a new job and you want to flex your data visualization skills, you can publish a lot of work in Tableau Public and link it in your CV so that the companies can see how skilled are you in Tableau. So all these nice features makes Tableau Public Cloud a very attractive platform for sharing visualizations. But now if you are talking about the security aspects, it is very limited. The only thing that you can control is not allowed to download your visualizations, or you can completely hide it from others, but you don't have any user access control like we have in Tableau server or cloud. So Tableau Public Cloud is a free cloud service from Tableau, which hosts a lot of reports and dashboards built by people all around the world. It's a great platform to get inspired by Tableau community, build connections to other Tableau developers, and share your skills. But since it's free, it comes with few limitations. The total size available for each account is only 10 gigabytes. Your dashboard and reports are not connected to the source systems. That means you cannot automatically refresh your data in Tableau Public. Always you have to do it manually. So you're gonna open the reports, refresh the data, and again publish it to Tableau Cloud. And the third limitation of Tableau Public is that, as the name implies, everyone in the world can see and share your data. That means you cannot use it in organizations since you cannot protect your data. Tableau Reader is a software you download and install at your PC. You can use it only to view reports and dashboards, but you cannot use Tableau Reader to create any data visualizations or even edit it. As you can see, we don't have any tools or functions to create charts. You can't even connect any data sources or refresh your data. Tableau Reader is a very old tool from Tableau. It was created in the early days of Tableau in order to share content built using Tableau Desktop. This was before even Tableau Server and Tableau Cloud made available. At that time, Tableau Reader was the only option you have in order to share dashboard and report with other users. So how it works? You build data visualizations using Tableau Desktop and then you send a file to someone else. Then they're gonna use Tableau Reader in order to view and interact with the dashboard that you built. So to summarize, Tableau Reader is a free tool. It is just to view and interact with report and dashboard built using Tableau Desktop. You cannot create or edit anything in Tableau Reader. You cannot refresh the data inside your dashboard using Tableau Reader. Each time you have to ask for a new copy if you want to have fresh data. And there is no security features, password protections, or login option. This is a big problem. If the files lands in the wrong hand, your organization data could be exposed. Well, I don't recommend at all using this tool in organizations. The risk is just too big. But if you want to take the risk and to share your visuals with 1, 2, 3 persons, then use it, but try to avoid it. Tableau Mobile is a free mobile app that you can download at your smartphone or your tablet. You can use it to view and interact with Tableau reports and dashboards published to Tableau Server and Clouds. So you can use it only to view the reports. You cannot use it to create new reports or to edit the reports. While Tableau Mobile is free to download, it requires a license to use. And it can only access Tableau Server and Tableau Cloud, so you cannot use it in order to access Tableau Public. And Tableau Mobile gonna automatically cache your reports and dashboards in memory. That means you can access them even if you are offline. Alright everybody, so now let's summarize and compare all Tableau sharing products side by side. The first point about hosting. Tableau Server can be hosted in your organizations or in cloud service providers like Azure or Amazon. Both Tableau Cloud and Tableau Public Cloud are hosted by Tableau team. Tableau Reader will just be software installed at your PC. You can't even host it. Now, if you are talking about the cost, for Tableau Server, you have to pay for licenses, hardwares, and maintenance. But in Tableau Cloud, you have only to pay for the licenses. Tableau Public and Tableau Reader are free to use. Now, if you check the data security aspects, both Tableau Server and Tableau Cloud are highly secure. Tableau Public and Reader, they are not. Next point is about the storage limitations. In Tableau Server, it really depends on the server disk space. In Tableau Cloud and Reader, there is no limitations, but in Tableau Public Cloud, the total size available for each account is only 10 gigabytes. The next point about the connectors. Tableau Server and Cloud can be connected to different types of sources like cloud, API, services, files, databases, and so on, but Tableau Public Cloud and Tableau Readers, they cannot be connected directly to any of your source systems. Let's jump to the next point, automation. In Tableau Server and Cloud, you can schedule tasks to refresh your data inside your dashboards automatically from the source systems, but the data inside Tableau Public Cloud and Reader cannot be refreshed. You have to do it manually. You have to republish it or to resend the file. The next point about Tableau Mobile, you can connect your smartphones or tablets only to Tableau Server or Tableau Cloud. And now to the last point, we can use Tableau Server and Cloud to share dashboards inside organizations. Tableau Public is used to share dashboards to the whole world, and Tableau Reader is used to share dashboards directly to individuals. Alright, so now with this we have an overview of all Tableau sharing products. So now the question is, when to use which product? So let me guide you in my decision-making process following this chart. Alright, first we ask all questions about the limitations inside Tableau Public Cloud. The first question, can data be public? If the answer is yes, then we ask the next question, should the data be frequently refreshed in the reports and dashboards? If the answer is no, then you can go and use Tableau Public Cloud. But if the data should not be public and should be refreshed automatically, then we have to think about private hosting. So the question now, do you want to manage the hardware? If yes, then you can use Tableau Server on premises at your organization. But if you don't want to do that and you want to outsource it, then you ask the next question, do you want to manage the software on your own? But if the answer is yes, then you can use again Tableau Server, but this time it's going to be hosted in cloud service provider like Microsoft Azure in IaaS service model. But if the answer is no, you don't want to manage the software by yourself and you want to outsource it, then you can go and use Tableau Cloud as a SaaS service. As you can see, Tableau Reader is not in my decision-making process since I don't recommend it at all. So now, if you combine this flowchart with the one that we built previously for developers tools, you will get my whole decision-making process that I usually use when I start a new Tableau project. So if somebody asked you when to use which Tableau product, you can go through it and find the right combinations for you or for your company. All those materials, you can find it in my website. Alright everyone, so with that we have covered all 8 Tableau products and we understood the differences between them. In the next chapter, we will learn the Tableau architecture to understand how Tableau internally works and what are the main components of Tableau. Tableau architecture. Now we're gonna go and understand how Tableau internally works, its components, and its limitations. So now we're gonna go and cover many important Tableau concepts, like what is live and extract connections, what are the different file types in Tableau, and then we're gonna start drawing the Tableau desktop architecture, and then we're gonna jump to Tableau server in order to understand different scenarios like the publish process, authentication process, and accessing view process. And after that, we're gonna go and complete the big picture by drawing the server architecture and its components, and at the end we're gonna cover as well the architecture of the Tableau public. So now let's start with the first concept, the live and extract data connections. So now let's go. How we come to the most important decision or questions that we're gonna make inside data source. Do you want to store an extra copy of your data inside Tableau? So here we have two designs for the data source. Either you're gonna say no, we don't need a copy inside Tableau, the data should stay where it is in the source systems. Then what gonna happen, each time your visualizations needs data, it's gonna send queries directly to the external database. And then the database gonna send the results back to your visualizations, so the data comes always fresh from the sources directly to your dashboards. This type of the connections, we call it a live connection. Or you're gonna say, yes, let's have a copy of our data inside Tableau. So a snapshot or subset of the data gonna be copied from the external database to Tableau. This copy, we call it an extract. And now each time our visualizations needs data, it's gonna send queries this time to the extract instead of the external database. And then the extract's gonna return the results back to your visualizations. And since the extract is inside Tableau and very close to the visualizations, we will get a great response time and very fast performance. This type of connection, we call it an extract connection. Alright, so now the question is, which connection type should I use in my data sources? The typical answer for this question is, well, it depends. Because here we have a trade-off between performance and data freshness. For example, if for you the performance is way more important than the data freshness, then you have to go with the extract, since the data gonna be stored inside Tableau in memory using the column store technique, you will get just great performance. But if you say, you know what, the data freshness for me is more important than the performance, then you have to go with the live connections in your data sources, because you will always get the fresh data directly from the sources in your dashboards. Alright, so now if you want to send Tableau files directly to the users, we have to ask the question, which type of files we're gonna send? Because in Tableau Desktop, we can generate not only one file, we can generate 5 different types of files in Tableau. So now we're gonna have like quick overview of those types of files to understand them and to know when to use them. Alright, so as we learned, the Tableau workbook contains 3 things: the extract, the data source, and the visualizations. There is a file type for each combinations, depend on your requirement. For example, if you want to share only your data without anything else, no data source, no visualizations, then you can send an extract as a hyper format. But now if you say, you know what, I've done a lot of work in the data source. I built a data model, I renamed stuff, I did aggregations, I created a lot of new columns. So I would like to share that with my team, with my colleagues. And I'm not allowed to share my data with them. So in this situation, you say, okay, I'm gonna share the data source with my colleagues, and we call it Tableau Data Source, TDS, without data. Or you might be in another situation where you say, you know what, my colleagues don't have an access to the source systems, we cannot use the live connection. And you don't mind sharing your data as well. So now you can send them a package of an extract and the data source. So the file type here called Tableau Package Data Source, TDSX. So this type of file contains both of your data and your data source. And we might be in another situation where our colleagues or users, they are interested as well in the visualizations. So we can send them a file with the visualizations and the data source. And here again, we have the same situation. You decide whether you're gonna send with it a data or not. So if you don't want to send the data inside it, you can send a file called Tableau Workbook, TWB. And the last scenario, I think you already guessed it. If you want to send everything, the whole package, the extract, the data source, and your visualizations, then you can go and send your colleagues a Tableau format called Tableau Packaged Workbook, TWBX. Alright, so as you can see, Tableau did design different types of files for different purposes. So depend on the situation or the scenario that you have, you can share your work with your colleagues. Alright, so now generally speaking, we have two different types of workbooks. A workbook with data using extract connection and another book without data using live connection. In one hand, in the workbook with data, you can send three different types of files. You can send only the data using hyperformat, or send the whole dataset with the data using TDSX format, or send the whole package with the format TWBX. And in the other hand, with the workbook without data, you can send only two files, the dataset without data, TDS, or the workbook WBX. And now you might have the question and you say, okay, which Tableau products should I use in order to open these Tableau files? Well, we have three Tableau products: Tableau Desktop, Tableau Public, and Tableau Reader. With the Tableau Desktop, you can open everything, you can open all these different Tableau formats and files, but with the Tableau Reader and Public, you can open only the Tableau Packaged Workbook, TWPX. Since Tableau Reader and Tableau Public cannot connect directly to the data sources and they cannot use the live connections. Alright, one more thing to understand about Tableau workbooks is that Tableau uses two different types of data to store the workbooks. The first one is the metadata information. It will be stored in XML files. Metadata is data about your data. It describes your data. It contains all informations on what have you done in the workbooks. Anything you click, drag and drop, or do while working with Tableau Desktop will be reflected in some way in the metadata. You can find informations, for example, like column names, data type, data model, and so on. And the second type is the data itself, the actual data. If you load data inside Tableau, Tableau gonna store it in format of hyperfile, where the data gonna be stored in column store methods in the memory of Tableau. It is like special formats for fast data retrieval. Alright, if you understand the Tableau architectures and how the components are connected to each other, everything gonna make sense for you as you are working with Tableau, and as well it's gonna make you a better Tableau developer. So I will be sketching the concepts in order to make it easier for you to understand. So let's go. The Tableau architectures contains four different layers: the source layer, the desktop layer, server layer, and the consumer layer. We will start unboxing each layer one by one to understand their components, and we're gonna work with this architecture from left to right. So we will start by the source layer and we're gonna end up by the consumer layer. Alright, so now we have the source layer. The source layer is outside of Tableau and it contains the source of our data. So our data could be in databases like MySQL or Oracle, or the data could be in files like Excel and JSON, or even in the cloud like Amazon AWS or Microsoft Azure, or even in APIs. So our data could be everywhere. Alright, so now back to the big picture, let's jump to the next layer. We're gonna unbox the desktop layer. The first component in Tableau Desktop is the data source. Before you start building your visualizations, you must set up the data source. The first thing that we're gonna do inside the data source is to connect Tableau to our data. Tableau offers around 90 different data connectors, so we can connect Tableau almost to anything. Once you build the connection between Tableau and your source of data, the access information is gonna be stored inside the data source. For example, the path of the file, location of servers, username, passwords, or access tokens, and so on. So all these information is gonna be stored inside the data source. Alright, so the two types of data connections in data sources are extract and live connections. So now we connected to data, we decided which type of the connection. The next thing that we have to do in the data source is to start building our data model. And we can do that by combining tables together using relationships, joins, and union. And you can do many other stuffs like setting the right data types, doing aggregations, renaming tables and columns, creating new calculations and filters, and so on. Alright, so now to summarize, the data source component in Tableau contains the following informations. We have the data connectors to connect Tableau to our data. We have the access informations where the locations of our sources is going to be stored. And as well, we can decide whether we're going to load an extra copy of our data inside Tableau. We call it an extract connection, or we're going to leave it as live connections in the data sources. And the last thing, we have the data model inside data sources, where we can combine tables together and do aggregations, or we can do some other custom stuff. Alright, so once we are done with the setup of the data source, we have the connection, whether it's extract or live, we have our data model and everything is ready. Now we're gonna go and start building our visualizations. And Tableau organizes the visualizations in 3 levels. The first one is the worksheets. So we can use the data available in our data sources to build a single view, only one visual. It could be a bar chart, a pie chart, or a table view. And as you can see, each worksheet is connected directly to a data source. But in Tableau, you can build a worksheet from 2 different data sources by using very powerful combining methods called data blending. And this is very unique feature in Tableau. You cannot find it in any other BI tools where the data in one visual can come from different sources. And once we have these different worksheets, we can go to the next level where we start combining these worksheets into one dashboard to show the different visuals in only one view. But keep in mind, if you want to do any changes in the visuals, you have to go back to the worksheets and do the adjustment there. And now we come to the last level, we have the stories. As you know, the main goal of doing data visualizations is to tell a story. So you can build like a sequence of worksheets or dashboards that works together in order to tell the users a story based on your data. Alright, so now you might ask me which visualization level is the right one for you. Well, if you have only one visual, then go with the worksheet. But if you want to build some kind of KPI to monitor process, then build a dashboard. And if you want to present your data and tell a story from it, then go and build a story. Alright, so now we have in Tableau Desktop both of the data sources and the visualizations, and these 2 components are contained in something called a Tableau workbook. So now the question is, after you're done building your data sources and visualizations, what can you do with this workbook? Well, you can share it with your colleagues in your team or department, and there is 2 ways to do that. Either you're gonna go and send a Tableau file directly to the users, or you're gonna go and publish the workbook to a Tableau server or cloud, and from there your users and your team can access your workbook. Alright, so now back to the big picture, the Tableau architecture. Let's talk about the layer on the right side, the consumer layer. There is different ways to consume Tableau visualizations, depends on the user's clients and on the tasks the users do. So we start with a very small group of users that they might use Tableau Reader to view and interact with Tableau visualizations, and they usually don't want to edit or create something new. For this group of users, we're gonna send them a Tableau file. As we learned, they're gonna need the Tableau packaged workbook TWPX. And we might have another group of users, usually they are your team colleagues, they want to build analyses on top of your work. They're gonna use Tableau Desktop to do that. For them, we can send any kind of Tableau files, depends on their requirements and their tasks. And now we have a big group of users or consumers that they can access Tableau server or cloud to view and interact with Tableau visuals. They can use their web browsers like Google Chrome and Firefox to access the content of Tableau server, and from there they can view, interact, and even edit the visualizations if they have enough permissions. Or they can use Tableau mobile app on their smartphones or tablets to view and interact with your workbooks, but they cannot use it in order to edit the Tableau visualizations. So for this group of users, you will not send them any files. First, you have to publish your work to the server. And here we have 2 options. Either you're gonna publish only the data source, or you're gonna publish the whole workbook to the Tableau server or cloud. And after that, you're gonna share the link of your workbooks to the users. And now to the last group of users that's worth mentioning, they are the static users. You can always export your data and visuals from Tableau Desktop and send it directly to the users as a PDF or Excel. So of course it's static and they cannot interact with it. Alright, so far in the Tableau architecture, we talked about the source layer, we did deep dive in the Tableau Desktop and its component, and we understood the different type of consumers and the clients. Alright, so previously we started sketching the Tableau architecture where we learned about the source layer, the desktop layer, and the consumer layer. Now we're gonna unbox the server layer in Tableau architecture. And in order to better understand Tableau server components, I'm gonna walk you through 3 scenarios from the user point of view. What's gonna happen exactly in Tableau server once we publish a workbook, or when we log into the server and access a workbook. So let's go. So let's say that you want to publish a Tableau workbook with an extract. What's gonna happen, Tableau Desktop gonna request the server to upload the workbook TWBX. And the first component in Tableau server that gonna receive the request is the gateway. The gateway knows how to forward the request to the right server component. And in this situation, the right component to process the publishing is the application server. So the gateway gonna forward the request to it. And as we learned, the Tableau workbook holds 2 different types of informations: the metadata stored in the XML files and the data itself stored in Hyper files. And in Tableau server, those 2 different types of files gonna be stored in 2 different places. The application server gonna send the XML file to be stored in the server component called repository, and the Hyper file gonna be stored in another component called the file store. So what we have learned so far: the gateway is responsible to forward the request to the right component. The application server is the one that's gonna handle the publish process. The repository gonna store the XML files, the metadata of the workbook, and the actual data, the Hyper, gonna be stored inside the file store. Alright, so now our workbook and our data are published to Tableau server. It's time now for our users to log into the Tableau server and start interacting with our dashboards. So let's see how this is gonna work. Let's say your manager is Michael Scott and Michael wants to check your sales dashboards in Tableau server.
And I am going to do it. I need a username. And I have a great one.
And once Michael gives these informations, a request gonna be sent to the server as HTTP request. The first thing that it's gonna hit is the gateway. The gateway knows that the application server is the right component to handle the authentication process. So the gateway gonna forward it to it. And then the application server gonna ask the repository to check if the credentials, username and password, are correct, and if Michael has permission to access our server. And then the repository gonna check, and if everything matches and Michael is allowed to access our server, it will respond back to the application server and gonna say, yeah, we know the guy, he is in our records. Then the application server gonna start building the server UI and send it back to the gateway, and then the gateway gonna send it back to Michael browser, and now he is inside our Tableau server. So what we have just learned from this process: again, the gateway is responsible of forwarding the request to the right component. The application server is the one that gonna handles the authentication process. The repository gonna store the user credentials and if the users have an access and permissions to our server. And the application server is the one that renders the web interface of the server. Alright, so now Michael is inside our Tableau server and he gonna start browsing and searching for your sales dashboard, and once he finds it, he gonna click on it and try to access your dashboard. So now let's see what's gonna happen in Tableau server. And as usual, the HTTP request for accessing gonna be generated and sent to the server, and we know by now that the gateway gonna receive the request and start forwarding it to the right component, the application server. And then the application server gonna start render the Chrome around the Viz, all those icons and images that are not inside the dashboard itself. And then the application server gonna say, okay, now we are talking about visualizations. This is completely out of my league. We have to forward this request to the master, to the brain. It is the VizQL server. It is the one that deals with visualizations. And from here, the VizQL gonna take over and gonna say, okay, first thing first, let's check if this guy Michael is allowed to see the sales dashboard. So the VizQL gonna ask the repository. And in the repository, there is a list of users and reports. So it's gonna search there to find any matches. If yes, then it's gonna send back, yeah, Michael is a boss and he's allowed to see the sales dashboard. And now the VizQL gonna say, alright, now we need data. So first we need the metadata of the dashboard. And as you know, after we publish the workbook, the metadata gonna be stored inside the repository. So the VizQL gonna request from the repository one more thing, is to send the XML file of the dashboard. The repository then gonna send back the XML to the VizQL server, and the server will start building the dashboard. Alright, so now the VizQL gonna say, okay, now we have the dashboard, but the problem is it is empty. We need the data to fill it. and it's better to ask our data specialist, and that is the data server. The data server is the one that knows everything about the data. So it's gonna say, alright, for this dashboard, part of the data we have it already inside Tableau server, but the other part is sadly outside of Tableau. To get the data inside Tableau server from the extract, the data server gonna send the query request to the data engine. And the data engine knows how to query and extract the needed data from the file store. So the data engine is gonna get the data from the file store and it's gonna send it back to the data server. And now we come to the part where the data is living outside of Tableau server. Here the data server gonna act as a proxy, where it's gonna use the data connectors to connect to the external databases. Once the connection is established, it's gonna send a query that matches the language that the database speaks. And then the database is gonna return the needed data as raw table. And now once we have all the needed data inside the data server, it's gonna combine it and do another security check. So the data server gonna check, is Michael allowed to see all data, or should we filter the data? So the data server gonna filters the data depends on the data security setup that you have made. And then it's gonna send the raw data back to the VizQL server. And now once VizQL server has the raw data for the dashboard, it's gonna do now the magic by turning all those numbers and raw data into images and visuals. And it's gonna put it inside the workbook. So now finally the VizQL has everything it needs. The sales dashboard is complete and ready. So the VizQL gonna send it back to the gateway, and the gateway gonna send it back to the web browser of Michael, so Michael can start interacting with the dashboard. And now, well, does Michael have any idea what to do with the sales dashboard?
I declare bankruptcy!
Alright, I know there was a lot of stuff going around in this scenario, but we have covered most of the Tableau server components. So let's have a summary and understand what we have learned so far. As usual, the gateway is responsible to forward the request to the right component. The application server is not responsible for the visualization process, but the VizQL server is the one that is responsible of building the visualizations. The repository gonna store information about the permissions and security, which users are allowed to access which dashboard, and the data server gonna manage both of the extract and live data sources, and the data engine is responsible of retrieving the data from the extract inside Tableau, and the data connector is gonna help the data server to connect to the external sources, and the VizQL server does the magic of transforming the raw data into visuals. Alright, so far with those three scenarios, we covered the most important component of Tableau server. In this video, you will learn about the Tableau server architecture. And then we're gonna do a deep dive into each server component of the architecture to understand how it works and what it does. And we start right now. The server layer contains mainly of three stuff. Two interfaces left and right, and in the middle we have bunch of server components. The left interface is the data connectors. They're gonna connect the external source systems to Tableau server components, and in the right side we have the gateway. It's gonna receive requests from different clients, and it's gonna connect it to Tableau server components. Alright, so now let's go more in details about the gate component. So in one hand we have requests come from different clients, like a login request from web browser or a publish requests from Tableau desktop. And in the other hand, we have different Tableau server components like the app server, VizQL server, and so on. And the gateway gonna be in the middle that knows how to forward the requests from different clients to the right server components. And the other task of the gateway is balancing stuff around. Let's say that you are working in multi-node environment where you have two nodes. When the gateway receives the first request, it's gonna forward it to the node number 1 since both nodes are free. But now if the gateway gets a second request, it's gonna say, oh, node 1 is full, let's process this request in node number 2 since it's free, and so on. Alright, so the gateway in Tableau server is like a distributor that knows everything.
You know someone like that?
Let's just say I know a guy who knows a guy who knows another guy.
So the gateway has two tasks. First, it routes the client requests to the right component, and second, it does load balancing if you are running Tableau server in distributed environment. Alright, so now we're gonna start talking about those Tableau components in the middle, and in Tableau server there is like different arts of components. We have servers, we have engines, and storages. And we're gonna start with the servers. As you learned in Tableau server, there is like different processes, the login process, publish, accessing a workbook, and so on. And in Tableau server, they designed different servers for different processes. processes. So let's start now with the application server. The application server is responsible for different processes. Like as we learned, a user login request gonna be forwarded to the application server, then the application server gonna check with the repository or an active directory, depend on your configurations, to find out if the user is allowed to access the server or not. And the other process the application server handles is the publish process, where the application server gonna get the publish request and it's gonna split the workbook into two files, the XML file to be stored in the repository and the Hyper file to be stored in the file store. And one more task for the application server is to render the server interface. All those little stuff that you find in Tableau server, like icons, images, projects, menus, it is the application server who render those stuff. So the application server is responsible for different processes, like the authentication and authorization process, the publish process, and rendering the server UI. But one process that the application server will never do is the visualization process. Alright, so now we're gonna jump to the next server. We have the VizQL server. This one gonna be interesting. Alright, so previously we talked about the power of visuals and how human brain transform text into visuals and images. The VizQL is like our brain. It's gonna do the magic by converting numbers and text into visual and images. VizQL stands for Visual Query Language for Databases. The founders of Tableau, Chris and Pat, they did invent this language. Let's say that you drag and drop something in Tableau, the VizQL gonna convert this action to an SQL query and then send it to the data server to get the data. Then the data server gonna send the results back to the VizQL as raw data. And now VizQL gonna do the magic by converting those raw data into visuals and images presented at your client. Alright, so the VizQL is the brain. It is very important Tableau component and responsible of the visualization process. And mainly it does two things. It's gonna generate queries from user action and it's gonna convert and transform the raw data into visuals and images. Alright everyone, so now we're gonna talk about the third one. We have the data server. So the data server is the one that knows everything about the data. It knows where to find the data, how to connect to it, and how to speak to it. The first task of the data server is to manage both extract and live data sources. If the data is inside Tableau, it's gonna send query requests to the data engine. But if the data is outside Tableau, it's gonna use the data connectors to send query requests to the external sources. And the data server knows how to speak to the sources. It acts like a proxy to the data sources, can speak many different database languages so that it sends query requests in a language that the database understands. And we have another task for the data server is to handle the data security. It checks if a user is allowed to see the data and do filterings if needed. And the data server manages as well the driver deployment. So the data server is the central data management component in Tableau server and the one that knows how to get data from the sources. Alright, so now let's jump to the next component. We have the data engine. If we decide to store our data inside Tableau as an extract, then the data engine gonna be the one dealing with it. Different components can send requests to the data engine. Like for example, the data engine can receive a request from application server to publish a new extract. Then the data engine can execute and create operation to create a new extract and store data inside it. The data engine can receive as well a query request from the data server asking for data. So what's gonna happen here, the data engine gonna find the correct extract, it's gonna connect to the hard driver, and then it's gonna pulse the needed extract from it. And at the end, the data gonna be sent back to the server. And finally, the data engine can receive a request from the backgrounder to update the content of an extract. So the data engine can execute an update operation by opening the extract and updating its content with the new data. So the data engine in Tableau is like any other database engine. It does different operations like it queries the data, it performs insert and update operations, and it creates new extracts. But only for the data inside Tableau server, inside the extracts. Okay, the next component is the repository. As you might already noticed, the repository was involved in every Tableau process. So let's talk about it. The repository stores many different types of data. Like for example, it's gonna store the workbooks that we publish to the server, but only the metadata part, not the data itself. So the XML files from the workbooks can be stored inside the repository. In the repository, we find as well the usage data. It's data that's gonna help you to understand the performance and the traffic about your project. Like for example, you can find the total number of active users inside Tableau server, what is the total view count by day, and you can find out the most used data sources in your project. Another type of data that you're gonna find inside the repository is the security informations. For example, which users are allowed to access your content or which users are allowed to access our Tableau server. Alright, so as you can see in the repository there is different types of data, and it contains as well huge amount of data in Tableau server, but it's very important to understand that is the data inside our dashboards and reports are not stored inside the repository. We have many other Tableau server components that's worth mentioning, like for example the cache server. It stores almost everything like images, icons, results of queries, dashboards and so on. So if you start a dashboard that is already accessed before, the data gonna be pulled from the cache server. Another component is the backgrounder. In Tableau server you can create a schedule to refresh the data inside your extract, and the task of the backgrounder is to check this schedule each 10 seconds and then trigger the process of refreshing the extract if the time comes. And the last component that I would like to mention here is the search and browse. The users of Tableau server, they can search for content, and this component is responsible for searching inside the repository and return the results to the users. Alright everyone, so finally we have the last puzzle, the server components. If we put it in the architecture, we will get the whole big picture of Tableau architecture. So now let's go and do a very quick summary. The source layer, it is the one that is outside Tableau and contains our data, and it could be anywhere like databases or files. In the desktop layer, the developers can start connecting Tableau desktop to the data sources with either copying the data inside Tableau using an extract connection, or with the live connections to the sources. Then the developers can start building visualizations using worksheets, dashboards, and stories. And both of the data source and the visualizations, we call it a workbook, and we can either send it as a file or share it to the server. The server layer gonna host our workbooks, and we can find many components, like the data connectors to connect our sources to the Tableau server, and the gateway to connect the client request to the Tableau server. And we have the application server responsible for the login and publishing processes, the VizQL server responsible for the visualization process, and the data server is the one responsible for the data management. And we have another component like the data engine that's gonna handle the extracts. And in Tableau server we have 3 places where the data gonna be stored. And we have the repository that contains many different data like the XML of the workbooks and the security objects, but not the data itself, because our data gonna be stored inside the file store as an extract. And we have the cache server that contains many different types of data to increase the Tableau performance. And the last one is the consumer layer. Here we found the different groups of users and clients, like the Tableau readers that needs only the TWBX files directly from the Tableau developers, and another group of users that they're gonna use Tableau desktop to develop new views. And we have the static readers that's gonna receive files like PDF and Excel, and then we have a big group of users that's gonna access Tableau server using either web or Tableau mobile to interact with the published workbook. Alright everyone, so one more thing that I would like to show you is this amazing dashboard from Tableau team. It's gonna show you the different components inside Tableau server and how they're gonna interact to do a task. So for example, if we go to the workflow or to the process, we can select, for example, access a view, and then we can select whether it's like an published extract or live. And over here we have like slider. If you drag it to the end, you're gonna see how the components are interacting with each other's to do the tasks, and on the right side you will see description for each step. And this is a really great way to learn how Tableau server works. I learned from this a lot for this tutorial, so make sure to check that if you want to see more details about other processes in Tableau server. I'm gonna leave the link in the tutorial materials. Let's start with the source of our data. In Tableau Public, you can only connect files like CSV, JSON, Microsoft Access, and Google Sheets. The next component is Tableau Public Desktop. It is a free version of Tableau Desktop. It's software that you can download and install at your PC. So here we start by connecting Tableau Public to our files by creating a data source. And in the data source, we have only one type of connection. It is the extract. So the data should be copied from our files to be loaded inside Tableau Public Desktop. So there is no live connection option. And then after that, we're gonna start building our visualizations, or we call it Vizes. And now once we are done building the views and the dashboards using Tableau Public Desktop, we have here only one option to share it. And that is to share the whole workbook, your data and the Vizes, to Tableau Public. And Tableau Public is a free platform hosted from Tableau team to share the visualizations from the whole world. And once our vises are published to Tableau Public, they can be now consumed from users all around the world. And here we have few options. The users can use their web browsers to view and interact with your visualizations, or users can download the whole workbook, your data and the vises in different formats like Tableau file, TWBX, or Excel, PDF, images, and so on. And the last option of consuming your vises can be embedded into your websites and blogs. Okay, so now since Tableau Public is free, it comes with few limitations. At the source level, we can connect Tableau Public only to files. The data connectors are very limited and we cannot connect, for example, to servers. And in the next level, at the public desktop level, there is limitation in the data source. We have only one type of connections, and that is the extract. So we cannot have a live connections to the sources, and the workbook itself, it can contain only maximum 15 million rows, and we cannot save the workbook locally at our computer. The only option to share it is to publish it to the Tableau Public. But there is like a workaround for that. I'm gonna show that in the next tutorial. Alright, so now let's move to the sharing level to Tableau Public. Here we have as well few limitations. For example, the total available size for each account is only 10 GB, and there is no way to refresh your data automatically. Each time you need new data, you have to manually republish the workbook with new data. And the third one, it's gonna be public, so there is no way to make it like private and to share it with only few people. You have always to publish it to the whole world. And now let's move to the final level. We have the consumers. The only limitation here is that you cannot use Tableau Mobile to access and interact with the visualizations. Alright everyone, so I decided to use Tableau Public in this Tableau course since it's free and all of you can follow me with the examples without having you to pay for extra licenses. And the limitations that we have in Tableau Public, they are not really relevant for the learning process. So the main features of Tableau, the data visualizations that we have in Tableau Desktop, they are all available as well in Tableau Public without any limitations. So don't worry about it. Alright everyone, so with that we have learned the Tableau architecture and its components, and we learned how Tableau internally works. And with that we have covered the theory parts of Tableau, and in the next section we will start preparing your environment so you can practice Tableau with me during the course. So let's jump in. Alright, so let's start with the first step. We're gonna go and download Tableau Public Desktop. So in order to do that, we're gonna go to the website public.tableau.com. I'm gonna leave the link in the description. And from there, we're gonna find the menu Create. And then we're gonna click on that. Then we have Download Tableau Desktop Public Edition. So let's click on that, and then we're gonna go to the middle and click on Download Tableau Public. And now before the download starts, we have to fill out this registration form. This is not for creating public account, it's just something before download starts. So we're gonna give the first name, last name, email, and country, and then we're gonna click download the app. And then the download gonna start. It's just 500 megabytes, so it should not take long time. And now we have the download is done, so let's click on the execution file to start the installation process. Okay, so at the start of the installation, we are at the welcome page, and here as usual we have to read and accept the terms, so you have to do that. And here we have second box. You can click on it if you don't want to send the product usage data to Tableau team. It's like cookies. I don't mind, I'm just gonna leave it. So we click now install. And once you do that, the installation gonna start. It should not take long time. Okay, so now the installation is done and Tableau gonna be launched automatically. Okay, so let's go back to the website public.tableau.com, and on the right side at the top we're gonna click on sign in, and then we have to click on this join now for free. Now we have to fill out this registration form in order to create a new Tableau public account. So we have to enter the name, the email, the password, and the country, and then we have to read and agree on the terms. And let's click here, I am not a robot, and at the end we're gonna click on create my account. And now we got the message to verify our account, so that means we have to check our emails in order to activate our account. So let's do that. Okay, so now after checking, I got an email from Tableau, so I'm gonna click on it, and then I'm gonna click on verify now in order to activate our account.
So I'm gonna click on that, and then it's gonna send me to my account, and with that we have brand new active Tableau public account. Well, it's like any other social media account. You can add your personal information. For example, we can add our photo or avatar. So let me check what I can do over here. So I have this photo from Stuttgart Television Tower. It's amazing there. And then I'm gonna click save. And we can add many other stuff. So let's click on edit profile. And as you can see over here, you can link your social media accounts or add your website and so on. So let's click save. If you want to learn any new tool like Tableau, Power BI, or any other programming languages, you need always a good dataset for training and practicing. I start searching for good training datasets, and after a lot of research, I downloaded like many datasets. But I was not happy with them. I didn't like them because they don't cover all the scenarios that we need for training. Let me tell you why this is an issue. In real projects, your data gonna be stored typically in data warehouses or data lakes inside many different tables. And the first step in any visualization tools like Tableau or Power BI is to connect those tables and combine them in one big data model. So training with only one table not gonna help you and prepare you for real projects. And that's why I decided to make my own datasets to cover all the training scenarios and to have multiple tables in order to learn how to combine them in one data model. And of course you can use my dataset in order to learn anything else like SQL, Python, Power BI, and so on. So let's see what I have prepared for you.
Alright, the first thing is that you're going to go to the link in the description, and then you're going to land in my website where I've collected all the course downloads and materials in one page. So for example, you're going to go and download the training datasets. We have here some important links, the 3 cheat sheets, and many sketch notes that I have prepared for this course. And then as well, you're going to find for each section what are the important links and sketches, and as well the Tableau files. This link going to be available for you after the course as well, so you can always come back here and download the stuff that you need. And of course for free. But now what we're gonna do, we're gonna go and download the training datasets that we need for our course. And here, as you can see, we have 2 zip files, one for the non-EU and one for the EU. So if you are currently in Europe, what you're gonna do, you're gonna go and download these datasets. But for all other countries, you're gonna go and download the first datasets, the non-EU training datasets. And now you might ask, what is the differences between them? Well, it's about the decimal numbers. Since in our datasets we have different decimal numbers like the sales, in different countries we have different representations of the decimal numbers. So all the European countries, they use, for example, the comma to separate the decimal from the whole number. But in many other countries, USA, in Asia, we have the dot in order to separate the decimal number from the whole number. And if you are using the wrong format, what's going to happen? Tableau will not understand that this field is a decimal number and it's going to convert it to string. So now, depend on your location, go and download the datasets. For me, I'm in Germany, so I'm going to go with the second one. And as I said, it's depend on your location. So let's go and click on that. So next, what I'm going to do, I'm going to go and grab the zip file and put it somewhere safe. So I don't want to leave it underneath the downloads. So I'm just going to create a safe path for that and then start extracting the data. Okay, so now let's go and unzip the files. So I'm going to go and extract all of them. Okay, so now let's go inside it and check the data. So here we have 3 different data sets. The first data set, the Tableau project sales dashboards. We're going to use it in the last section once we start building our project. Then we have 2 other data sets, the big data sets and the small data sets. We're going to use these 2 data sets in the whole course. So the small data source and the big data source, they are very similar. So now you might ask me, why do we have 2 data sets? Okay, so now let's open both of them and see what do we have inside them. So as you can see, we have almost the same tables. So customers, we have orders, products, and so on. So they are almost identical. And now you might ask me, why do we have 2 datasets? Well, because we have many different types of calculations and functions. For example, some calculations gonna change the data at the row level, and it's better to have a small dataset in order to understand the results easily. And in the other hand, we have calculations like aggregations on the table, LOD. It's better to have many data in order to understand how it works. And that's why I have decided to have 2 datasets in order to cover all those scenarios. And another thing about the datasets is that the file type is CSV. We have only one JSON over here, so you can use either Tableau Public or Tableau Desktop in order to follow me in the course.
Alright, so now I'm gonna walk you through the data model of our datasets. Here we have three typical tables. Our datasets contain information about the superstore use case. It is simply sales transactions of customers ordering products by a company. It's classic and very easy to understand. The first table in our data model is the customers table. It contains all customer informations such as the name of the customers, their locations, and their score. In the small dataset we have 5 customers, and in the big one we have around 800 customers. And the second table in our data model is the orders. It contains all the orders placed by the customers. So we have informations like the order date, sales, quantity, and profits. In the small datasets we have 10 orders, and in the big dataset we have around 5 years of data, and that's really helpful once we start building clusters. And the third table in our data model is the products. It contains all the products that we find inside our superstore. So we have informations like the product name, category, and the subcategory. In the small dataset we have only 5 products in the category monitor and accessories, but in the big datasets we have more than 2000 products with categories and subcategories. Alright, so now we have those 3 tables, but as well we have relationships between them. Like for example, there is a relationship between the orders and customers. They can be connected using the customer ID, and if you check the orders and products you can find another relationship between them where you can find the product IDs in both tables, and with that we can make a relationship between the orders and products. Alright guys, so I left all those informations in my website. You can find there all the links to the datasets that I found during my research, so you can go there and check them if you want. Okay everyone, so let's start Tableau Public Desktop if you don't have it open already. And then in the starting page we're gonna go to the left menu to connect Tableau to our data. So click on text file. And now we're gonna go and find our file, the customer CSV that we just downloaded. And now we can see the customer's data inside Tableau. So let's move to the worksheets. I'm gonna click on the orange tab over here, sheet 1, to create a new worksheet. And now we're gonna build our visualization in Tableau. We have only to drag and drop. So from the left side, let's drag and drop the country in the columns. And let's get another one. Let's move the count to the rows. Alright, so that was it. We have our first viz. And here you can see in this visual how many customers we have in each country. So with that, we are done building the workbook, and now it's time to share it. So sadly in Tableau Public, we cannot download it locally at our PC, but I'm gonna show you a workaround later. So now the only option that we have is to publish it to our new Tableau Public account. Okay, so now in order to do that, let's go to the main menu over here, then click on Files, and then we're gonna click on Save to Tableau Public. For the first time, you have to sign in with Tableau Public account that we just created. Alright, so now let's click on Sign In, and now we have to give it a name. I'm gonna call it my First Viz. And once you click Save, Tableau Public Desktop gonna start publishing our workbook to Tableau Public. And once it's done with the publishing, a web page can open automatically, directly showing your viz in your public account. So here's our viz. Let's go back now to our home page. And as you can see over here, we have our first viz published to Tableau Public. And let's go inside it again. And now everyone in the world can see your viz, interact with it, and even download it. So let's see how we can download that. There is download icon over here, then click on that, and now you can select the file format that you want. Let's select the last one is Tableau Workbook. So click on that, and then click download, and now we will get the Tableau file TWBX, where we have our data and our visualizations inside it. So if you open it, you can see our work again. And this is the workaround that we can use in order to save our work locally at our PC in Tableau Public. Now, I remember in 2014, the first time I opened Tableau, I was overwhelmed with all icons and bars that we have in Tableau Interface, and navigating through Tableau pages was very confusing for me at the start. And that's why I'm gonna take you in a short tour in Tableau Interface. So let's go. Okay, so now let's go and start Tableau. And now the first thing that I want to show you is that the whole file, we call it a workbook. And the workbook is like any other book. It contains different sheets. And the Tableau workbook contains 3 main pages. We have the start page. It is the main page where you can connect our data to Tableau. And then we have the data source page. It is the place where you can connect and combine your tables together and do changes to the metadata like renaming columns and so on. And the third page where you're gonna spend most of the time is the workspace page. It is the place where you're gonna build your data visualizations. Alright, so now we're gonna learn how to navigate through those pages and how to switch between them.
Okay, so once you start Tableau, you will be in the welcome page, the start page. And now if you want to go to data source page, we have to connect something. So let's go again to the left side over here, connect to text file, and then select our file customers and open. Once we do that, we're gonna land automatically in the data source page. And now if we want to go back to the start page, so in order to do that, we're gonna go to this Tableau icon over here on the left side. So if we click on that, we're gonna go back to the start page. And if you want to go back to the data source page, we're gonna click on the same icon. So click on that again, and we are back to the data source page. So with this icon, we can always go back to the start page of Tableau. All right, so now let's see how we can go to the workspace page. In order to do that, we're gonna go to the bottom over here. You will find different tabs. The first one is always the data source tab. This is exactly where we are now at the data source. But now if we select the sheet, Tableau gonna take us to the workspace page. And if you want to go back to the data source page, there is two ways to do that. First, we can stay at the bottom over here and we can select the data source tab. So by clicking on that, we go back to the data source. And the second option is that add a data pane. So if you go to the left side over here, you can see our data source customers. And if you double click on it, we're gonna go back to the data source page. Okay guys, so that was it. This is how you can navigate through Tableau pages. Let's have now a quick overview of each page. Okay, so let's start with the first page, the start page. We can see here three panes: Connect, Open, and Discover. In Connect, we can find all different types of data connectors, and in Tableau Public, we have around 10. That's enough for the training, but in Tableau Desktop, we have over 90 data connectors. And now in the middle, we have Open. Once you start Tableau for the first time, this section gonna be empty, but as you start creating new workbooks, Tableau gonna start showing you the most recently opened workbook. And this is really nice to have quick access to our workbooks. Here we have only one, the First Viz that we published before. And on the right side, you will find Discover. You will find different stuff from Tableau team like blogs, news, training, tutorials, and so on. And now in the bottom, you can see informations about Tableau software. For example, now it shows that we can upgrade to Tableau Desktop. Or later, once Tableau releases a new version of Tableau, you will find information here to update your Tableau. But since we just installed the most recent version of Tableau, it doesn't show it. Okay, so that was it for the start page. Let's jump now to the next one. We have the data source page. And by now you should know how to go there by clicking on Tableau icon. Okay, so what do we have here in the data source page? On the left side, you can find all informations about our data. In connections, you can find the connection informations, and in files, you can find all tables that are inside our data. And then in the middle, we have the data source name. And then over here, we have the area where we're gonna build our data model, and it contains two layers: the logical layer and the physical layer. I'm gonna explain that in the next tutorials, don't worry about that. And beneath that, we have the data grid. It's gonna show us a sample of our data, and as default, it's gonna show the first 1000 rows of data. And in the left side, we have another grid. This is the metadata grid. It shows us more details about the table's fields. Alright, so that's all for now. We're gonna move now to the next page, the workspace page, and we can do that by selecting the Sheet tab. Okay, so in the workspace page, we're gonna spend most of our time here building our visualizations. That's why we have a lot of icons and stuff around. So let me quickly guide you here in this interface. Okay, so we're gonna start on the top. We have the toolbar. It contains a lot of icons, and those icons are the most frequently used functions in Tableau. So as you are building your visualizations, you have a quick access to those functions. And as you might already notice, there's some functions that are not selectable. Well, you have to understand here that in Tableau, if something is grayed out, that doesn't mean that this feature is not available in Tableau Public, but it means it is not relevant for the visual now. So for example, if I go over here, it's gonna sort the visual, and since I don't have anything, so it's not relevant to sort it. Let's check the other icons. We have the Tableau icon. It's gonna take us to the start page. You know that already. We have the undo and redo, the last action in the visual. And as you can see, as I'm hovering on the icon, Tableau gonna give me short description of the function. So here we can create a new data source, or over here we can create a new worksheet, and so on. So just hover on the icons and you will see the function. Alright, so now let's move to the left side. We have here two panes, the data pane and analytics pane.
As default, Tableau gonna show us the data pane, but if you want to go to the analytics pane, just simply click on it. So you can switch between them by just selecting them. So let's see what do we have here in the data pane. The first thing is the data source that contains our data, and below that we can find the tables inside this data source. We have currently only one table, the customers, and we can see over here the fields or columns inside our tables. And here we have as well a search field. Sometimes our data source gets really big and we're gonna have a lot of fields, so this is a really nice way to search for specific field. Okay, so now let's go to the analytics pane, and you can find over here predefined functions that you can add to your visual, like adding an average line or doing clustering, or even you can create your own reference line. Really nice stuff. Okay, so now I'm gonna switch back to the data pane. Alright, so now let's move to the middle, and you can find over here different shelves and cards. We're gonna use them in order to build our visualizations, and everything works here with drag and drop. So let's start with the first one, the rows and column shelves. The visuals of Tableau, they have two dimensions, the rows and columns, like any other tables. So if you put fields in the column shelf, it's gonna create a column of the table, while if you put fields in the row shelves, it's gonna create a row of the table. Easy stuff. So now let's have an example. Okay, so let's go to the left side, and we're gonna drag and drop the countries on the columns, and with that we define the columns of the visual over here. So now we're gonna have something in the rows. Let's take the counts and drag and drop it on the rows. And with that, we define the visuals, columns, and rows. So if you want to swap between them, you can go to the toolbars over here and click on this icon. And you can switch between them very easily if you have a lot of columns. I'm gonna switch back. And now we can add more columns and more rows. So for example, let's take the city, drag and drop it on the columns over here. So you can have multiple stuff. And now if you want to remove one of those columns, you can do that by drag and drop on the empty space. Okay, so let's move to the pages shelf. You can use it to split the current visual into series of pages if you want to analyze something like step by step and take it slowly. So let's have an example. Okay, so let's take again the customer count, drag and drop it on the pages. And now as you can see on the right side, we have a new window to control the pages. And now we are at the first page where we have countries with only one customer. So if we click over here on the right side, you will get the countries with 2 customers and so on. And now for the next example, I'm gonna remove it. So I'm just gonna drag and drop on the empty space. Alright, so let's move to the next shelf. We have the filters. You can use it in order to filter our visual. For example, let's take the countries, drag and drop it in the filters. And now you can here decide which country is gonna stay and which country is gonna leave the visual. So now if I select, for example, let's remove France and click apply, you can see our visual don't contain now the country France. And now I'm gonna remove it again from the shelf by drag and drop in the empty space. And then we have the marks card. You can use it in order to design the visual. So for example, we can add new colors. So if we drag and drop the countries on top of the colors, we will get a color for each country, or we can change the size of the bars, either make it small or big, or we can add labels and so on. Okay, so now let's move to the middle. Of course, here we have our view. It contains visualizations, or we call it vizes. So first we have the title, and you can change it by double click on it. Let's give it a name, for example, customers by country, and then click OK. Okay, and below that we have our visualization, and it contains different stuff. For example, we have the headers, and here we have the countries, and as well we have the axes. Now the intersection between those fields are the marks. And those marks could be like bars in this example, or could be a line or circles or any other shape. And now if we check the bottom of Tableau Interface, you can find status bar. It contains a lot of details about our visual. For example, it says we have 3 marks. Of course, we have 3 bars, and we have 1 row and 3 columns. And the total number of customers is 5. And now let's add more stuff to the visual to see how those status change. So let's take the scores, drag and drop it in the rows. And you can see here we have now 6 marks, we have 6 bars, we have 2 rows and 3 columns. And those status are really important once your visualizations get complicated. So now we have very simple one, we can count it and see we have 6 bars, but if we have a lot of dots and a lot of points, it's really hard to count them, so it's really nice to check the status bar to see details about our visual. Alright, so now let's move to the right side and we're gonna go to the show me icon. So select that, now you will get different visualizations that Tableau offers, and by just clicking on them, you're gonna switch the whole visualizations in our view. So here we can switch it to tables, or to pie charts, or to tree maps, and so on. So now just go and explore those different visualizations, and you might already notice that some of them are grayed out, we cannot use it. Here again, it's available, but we don't have the requirements to use it. So for example, if we go to the line chart, here Tableau tells you what are the requirements or what Tableau needs in order to build this visualization. So it needs one date, it doesn't need any dimensions, and it needs at least one measure. And currently in our view, Tableau cannot create it because we don't have any date field in our view. Alright everyone, so that was the main component of the worksheet. Now before we go to the dashboard, I'm gonna do a few stuff, you can follow me. Okay, so I'm gonna undo those visualizations and go back to the bar. And then I'm gonna create a new sheet. So I'm gonna click over here, create a new worksheet. And then I'm gonna take the countries. And this time I'm gonna take the scores over here. And then I'm gonna use the pie charts. And over here, I'm gonna put some labels on it. Okay, so that's enough. Let's go now to the dashboard. We can do that by creating a new dashboard on the icon over here. And now we are at the interface of the dashboard. I'm not gonna explain everything over here. It's just important to understand that in the dashboard, we can start combining different sheets in one place. So we can drag and drop the sheet number 1, where we have the customers by country. And then we can take the sheet number 2, just place it somewhere over here. And then I have in one place 2 visuals, the sheet number 1 and sheet number 2. And this is the main job of the dashboard. All right, everyone. So now I'm going to show you the last type of sheets. We have the story. In order to create a new one, we're going to go to the bottom over here and click on this icon. And with that, we have created a new story. And stories in Tableau, they are like sequence of visuals, and we use it usually for presentations if you want to tell a story from our data. Alright, so what do we have over here? In the left side, we have the visuals that we created. We can see the worksheets and as well the dashboard. And then over here, we can add a new story points. And in the middle, we have in this section like navigator to go through our story. And then here we're going to present the story or the views. So what we're going to do now, in the first one, we're going to drag and drop the dashboard. Let's do that. And now we're going to add a next step by adding blank over here. And then we're going to take the sheet number 1 and then we're going to add a new one, blank, and then sheet number 2. So now we have like story. It starts with the big picture with the dashboard. And as we go through the story step by step, we go more in details in each visual. It's a really nice way to present or to tell a story using our visuals. All right, so now we have the Tableau software installed. We have the 2 training datasets, the public account to share your work, and everything is ready to start learning Tableau. So with that, we have finished this section where we have prepared your environment to practice Tableau. And in the next section, we will do deep dive in the Tableau data source to learn how to build a data model in Tableau by combining tables. Data modeling in Tableau. Each successful dashboard or charts in Tableau can be based on a solid data model. And having data modeling skills is essential for each Tableau project or business intelligence projects. So that's why we're going to start learning the fundamentals of data modeling, including the star schema and the snowflake schema. And then I'm going to introduce you to the Tableau data modeling, where you're going to learn the physical and the logical layers. And then we're going to learn the different methods on how to combine tables in data modeling using joins, union, relationships, and data blending. And of course, in order to understand the differences between them, we're going to compare them side by side. And of course, I'm going to guide you in when to use which methods. And at the end, we're going to go and build 2 data sources based on our training datasets. So let's start with the first topic, where we're going to understand the fundamentals of data modeling. So now let's go. In real projects, your data can be stored typically in data warehouses or data lakes inside many different tables. And the first step in any visualization tools like Tableau or Power BI is to connect those tables and combine them in one big data model. So let's start with the question, what is data modeling? Data modeling is the process of organizing and representing data in a clear and understandable way. Each data model has entities. Entities could be things like customers and products, or events like orders. And inside those entities, we have informations, and we call them attributes, like the first name and the last name inside the entity customers. And we describe in the data model how those entities are connected or related to each other. And we call it relationships. This data model, this visual representation of the data, makes it easier for us and for programs to understand the data, which is really important for making decisions and improving performance of the business.
Alright, so we have three different types of data models at different levels of abstraction. First, we have the conceptual data model. This type is high-level representation of the data model without going in details on how the data model is implemented. It's like a map that shows the important entities and their relationships. And we usually use this type to explain the data models to business analysts and stakeholders to understand the big picture of the data. The second type is the logical data model. In this data model, we go more in details on how the data is structured and organized. We define in this model the attributes of each entity, and it includes as well constraints and more details about the relationships between the entities. This data model is usually used by database designers and developers as a blueprint for the implementations. And the third type is the physical data model. This type represents the actual implementations of the data model. It includes all the technical details about how to store the data, like the data types of the attributes, the primary and foreign keys, indexes, and so on. This data model is used by developers to create and manage the databases. Alright, so let's summarize. The conceptual data model shows the big picture of the data. The logical data model provides a blueprint for the implementations, and the physical data model shows how the data is implemented in the databases. And Tableau did adopt both the logical and physical data models in the data sources, but we don't have conceptual data model in Tableau. Don't worry about it, I will show you more details later. Alright, so now for analytics, and especially for data warehousing and business intelligence, we need special data models that are optimized for queries and for analytics. It should be flexible and easy to understand. And for that, we have two special data models. First one is the star schema. Star schema has a central fact table and surrounded by dimensional tables. The fact tables contains events and the dimensions holds descriptive information. The relationship between the fact and the dimension tables form a star shape, and that's why we call it a star schema. And the other data model, we call it snowflake schema. It is very similar to star schema, but the dimensions here are breaking down into sub-dimensions. Normalized tables or dimensions means that those tables are broken down into small pieces to avoid having big tables or big dimensions, which leads to many data duplications and slow performance. The shape of these data models looks like a snowflake. So star schema is a simple and easy to understand data model, and we usually use it if our dataset is small or medium. In the other hand, the snowflake schema is more complex, but it eliminates the duplicates and reduces the storage spaces, and we usually use it if we have large datasets. Alright, so the datasets that I've prepared for this Tableau course are using the star schema data model just to keep it simple and easy to follow. Alright, so our data model has a name and we call it star schema. If you're gonna work on real projects, you're gonna hear about the star schema a lot. So star schema has mainly two types of tables, facts and dimensions. For example, we have the table customers. It describes each customers by their first name, last name, country, and so on. So customers is a dimension table. And we have another dimension table in our data model. It is the products. So products table describes as well each product by their name and category. So it is as well a dimension. Alright, so now let's talk about the second type of tables in the star schema. We have the facts. For example, let's have a look at the big table in the middle. We can see three things. You can see first a lot of keys to the other dimensions. We have the order ID, customer ID, product ID, and we can see dates. So we have the order date, the shipping date, and the third thing, we can see a lot of numbers. So we have sales, quantities, profits. We call them as well measures. So if you see those three things, that means we have an event or fact table. So facts connect dimensions together, it has dates and as well measures. Okay, so to summarize, how do we decide if a table is dimension or fact? If you have a table that contains information about a physical person or an object like employee, customers, products, then this table is a dimension and usually they are small tables. And in the other hand, if you have a table that contains events, for example, we have sales, orders, logs, ATM transactions, so any tables that has events, transactions, and has time in it, we call it facts, and usually they are really huge tables. Okay, so in our data model in the datasets, we have two dimensions. We have the customers and products, and in the middle we have our fact, the orders. Alright, so now if you hear in your project someone talking about star schemas and so on, you know exactly what they mean. It's very important concept in analytics and BI world if you are using Tableau or Power BI. Okay, so once we connect our data to Tableau, we have to create a data model in our data source. And if your data contains only one table, then your data model is very simple. You have single table in your data model. But in real life projects, things get more complicated where you have multiple tables. And Tableau here offers 4 different methods of how to combine and connect your tables. We have relationships, joins, union, and data blending. And now before we start doing deep dive in those 4 methods, let's first understand the data modeling in Tableau. In Tableau data model, we have 2 layers. We have the physical layer, and on top of it, we have the logical layer. In the physical layer, we might have some couple of physical tables, and we can combine them in Tableau using 2 methods, either joining the tables or using union between them. And now let's move to the logical layer. It is the top level layer and provide us like an abstract to hide all the details in the physical layer. This is especially nice if we have a lot of tables in the physical layer. So once we are building our visualizations, we don't want to see all those tables in the physical layer, so the logical layer gonna provide us like an abstract or gonna hide all those details. So the result of merging the tables using join and union in the physical layer gonna be presented in the logical layer with single table, flat table, and we call it a logical table. So that means we're gonna have 2 logical tables. The first one gonna present 3 tables after doing the join, and the second one gonna present 2 tables using the union. But we still have in data modeling to connect those 2 logical tables, and in Tableau we have only one method to do that, and we call it relationships. And it's very important to understand that in the logical layer we cannot merge tables in one table. So after we connecting them using the relationship between the 2 logical tables, the table is gonna stay as it is and nothing gonna be merged. We just describe the relationship between the 2 logical tables. And now back to those 2 layers, both of the physical layer and the logical layer, we can find it inside Tableau data source. And as you know, on top of the data source we have our visualizations, and you can see in this example only the table from the logical layer, and you can start building your visualizations using the data available from the logical layer. But sometimes as you are working with the projects, you build another data source with another data model. And here in this example, it's important to understand that not all logical tables comes from the physical tables. They could come directly from your source system. And now in order to build one visualizations from both of the data models and the data sources, we have somehow to connect those 2 data models or data sources, and we can do that in the visualization level where Tableau offers us the last and very unique method of connecting and combining tables, something called data blending. So by looking at this, you can see that Tableau offers us 4 different methods of how to combine and connect tables in different layers and different levels. So in the physical layer, we have the joins and unions, we have in the logical layer the relationships, and at the visualization level, we have data blending. Alright, so now let's see in Tableau how we can navigate through the physical and the logical layer. We are currently at the data source page, and as a default, we're gonna be at the logical layer in the data model. So that means anything that we drag and drop in our data model gonna be considered as a logical table. So the customers is a logical table. Let's take another one. Let's take the orders, drag and drop it over here. So this is our second logical table, and as you can see, Tableau did create between them a relationship, because at the logical layer we can do only relationships. So now we are at the logical layer. How we can go to the physical layer? In order to do that, we're gonna go inside a logical table. So let's go to the customers and double click on it. Once we do that, we're gonna go to the second layer. We are inside the physical layer now. So Tableau gonna tell you over here, the customers is made of one table because we have only one physical table. So now anything that we drag and drop in the data model gonna be considered as a physical table. So for example, we can take the customer details. Let's drag and drop it over here. And by default, Tableau gonna create between them not a relationship. It's gonna create a join between those 2 physical tables. And of course, we can do a union between them. So in the physical layer, we can do joins and unions. And as you can read over here, it says the customers, the logical table customers, is made of 2 physical tables. And if you hover on this icon, you will see exactly that. So we have 2 physical tables defines the logical table customers. And now if you want to go up back to the logical layer, we can do that by just closing the physical layer. So let's click on that. And now you can see that the customers has a new icon. It says in the physical layer, there is like a join. And we get more information if we hover on the tables. It says logical table customers that is made of two physical tables, the customers and the customers details. So that means the data in the logical tables comes from the physical layer. But if we go to the orders over here, you will see no physical tables. The data comes directly from the original tables. And with that, we have learned how to navigate through the physical and the logical. Alright, so let's start talking about joining tables. We usually have two tables, table A and table B. And if we want to combine them in one big table, then we can use join between them. The first thing to understand is that once we use join between two tables, then we have two sides. Table A gonna be the left table, and table B gonna be the right table. So now what gonna happen after we join the tables? All the fields from the left table will be at the output, and then all the fields from the right table will be added next to it. So joins combines the fields or the columns of two tables. So now in order to do joins, we need two things. First, we need the key field. It is a field that you can find it in both tables. And after that, we have to define the type of join, and we have to choose between 4 different types of joins. We have the inner join, the left join, right join, and full join. And if you know SQL, then you know those types. It's exactly the same logic. But let's have a quick examples to understand the 4 types of joins. Alright, so now we have this example where we have 2 simple tables. We have the customers' names and the customer's age, and we want to combine them in one table because it makes no sense to have 2 tables about the customers. So we want to make one customers table and we want to combine them. In the first table we have the ID and the names, and the second table we have as well the IDs and the age. So it's really easy. The key for this join is the customer ID. And now let's see the different output using those different types of joins. So let's start with the first type of join, the inner join. Inner join says the output gonna show only the matching rows from the left and from the right. So that means any unmatching rows will not be presented at the output. So let's see how this works. So the first thing that's gonna happen is that we're gonna combine first the fields. So first we're gonna start with the left side and then the right side. And now we're gonna start matching the rows. We're gonna start from the left side. Do we have the user ID 1 in the right side as well? So we have a match. So in both tables, we have the customer ID 1. So this, we're gonna see it at the output. And then we proceed on the left side. Do we have customer ID number 2 as well on the right side? You see, we don't have it. We have only the customer number 3. That means 2 is not matching on the right side, and as well the customer 3 is not matching on the left side. So that was it. If you use inner join in this example, you will get only the customer ID number 1 since we find it in both tables. Okay, so let's go to the next one. We have the left join. Left join says we're gonna have everything from the left table without checking anything, but from the right table we're gonna have only the matching rows. So if we do left join between those 2 tables, we're gonna have the following output. So first we're gonna have the fields from the left table and the fields from the right table near each other, and then we're gonna have all the customers from the left table without checking anything. So everything gonna be presented over here, those 2 customers, and then from the right side we're gonna have only the matching rows. So that means, do we have the customer ID number 1 on the right table? Yes, we have it. Then we're gonna have it at the output. But the customer ID number 2, we don't have it at the right table, which means it's gonna be empty, and empty means nulls. So here we're gonna have the values of nulls in both of the field ID and as well in the age. And that's it. This is the output of left join. Alright, so now we're gonna move to the next one. We have the right join. You might already understand how it works. So we're gonna have all the rows from the right table and only the matching rows from the left table. So let's see how the output gonna be if we do right join between those 2 tables. As usual, we're gonna have all the fields from the left, all the fields from the right, and we're gonna have all the rows from the right table without checking anything. So we're gonna have those 2 customers, and then we start matching from the left side. So do we have the customer number 1? Yes, we have it. So we're gonna add it over here. Do we have the customer number 3? So as you can see, we have only the 2. That means we don't have informations, and we're gonna have the nulls. So those gonna be empty. And that's it. So it is exactly the opposite of the left join. And now to the final type of join, we have the full join. Full join means
everything from left and everything from right without missing anything. So let's see what's gonna happen if we have full join between those two tables. So as usual, we start with the fields, so from the left and from the right, and then we take everything from the left side, so we take those two customers over here, and from the right side we're gonna have the matching rows for those two customers. So for the ID number 1 we have this one, but for the 2 we don't have any matching rows, so we're gonna have nulls over here. But as you see, we don't have everything from the right side, so the customer ID number 3 is missing. So that's why using full join, we're gonna have those informations over here, and then we're gonna match it as well from the left side. So do we have any customer number 3 on the left side? We don't have. So that means we're gonna have nulls as well. So now by checking the output, you can see we have everything, all the data from left, all the data from right, and where there is no match, we're gonna have nulls. So as you can see, you need to be really careful with the type of join you are using, because using the wrong one, this could cause of losing data. And if you want to be safe and you don't want to lose any data, then you have to use the full join, but sadly full joins are very slow and you're gonna end up having very big tables, especially if both tables have a lot of unmatching rows. And now I want you to understand how joins works in Tableau and what can happen in the background once we join tables. So we have the data source, we have the visualizations, and inside the data source we have the physical layer and the logical layer. In the physical layer we're gonna join both of the tables A and B, and once we do that, Tableau gonna create one new combined table A and B in the logical layer. This table, we call it a logical table, which contains data from both tables. And then in the visualization layer, let's say we want to select the fields of F2 and F4. So Tableau gonna query the data source, and the data source gonna get the data from the new combined logical table AB, and then send the data back to the visualizations. So as you can see, the interaction between the visualizations and the data source gonna be at the logical layer. So the physical layer gonna be completely out of the picture. And that's simply how joins works in Tableau. Alright, so now how we can do joins in Tableau. Let's say that we want to join the table customers with the orders. So first we're gonna go to the left side over here, drag and drop the customers, and the join is gonna be done at the physical layer. So we have to go there. So let's go inside the customers, and now we are at the physical layer, and we're gonna take the orders and just drag and drop it over here at the empty space. And with that, Tableau as default gonna create an inner join between the customers and the orders. And if we want to customize the join, we're gonna go over here at the icon and click on it. And we have here two things to do. First, we're gonna define the type of join. As we learned, we have the inner, left, right, and full outer join. You can just click between them and see which data gonna be missing and which data can be presented, as the example that I showed you. So I'm gonna stay with the inner join, and the next thing is that we're gonna define the key for the join. So Tableau did understood there's customer ID from the left, there is customer ID on the right, and this is the perfect match, which is correct. But let's say it was wrong and you want to choose the correct key for the join. What you're gonna do, you're gonna go to the left side over here, click on the arrow, you will get all the fields from the left table and select the correct one. In this example, the customer ID is correct, so I'm gonna stay with it. And you'll go to the right side, you have as well the same icon over here, and you will get all the fields from the right table and you select the one that suits you. And one more thing, your key for the join could be not only one field, it could be multiple fields. So you can add more fields over here. So you go to the next row and select the next field for the join. But in this example, we have only one key. So I'm gonna close this. We have set up the joins. We're gonna stay with the inner join, and we can go back to the logical data model. And as you can see, the table over here has the icon of join. It tells us that this logical tables is a result of joining two tables. And that's it. This is how you can do joins in Tableau.
Alright, so that's all for joins. Next, we will learn the second method, how to combine tables using union. Alright, so now let's talk about union. Let's say that we have two tables and both of them has exactly the same columns. Sometimes it makes sense to combine them in one big table, and we can do that using the union. So once we do union, what's gonna happen? The columns and the rows of the left table gonna be presented at the output, and from the right table only the rows gonna be appended at the output beneath the first one. So union gonna combine the rows of two tables. And in order to do the union correctly, we have two requirements. First, both of the tables should have exactly the same number of fields, and second, the fields should have exactly the same data types. So as you can see, we don't need a key between those two tables. It's not like the join. Alright, so now let's have a quick and very simple example about the union. We have here very simple two tables, the orders of 2022, the orders of 2023, and as you can see, both of the tables has exactly the same structure. So we have two columns, the ID and date in both tables, and it makes sense to merge them in one table. We call it orders. So if we do union between them, what's gonna happen at the output? It's gonna start from the left table, and it's gonna take the fields first, so the ID and date, and then it's gonna take all the rows from the left side and put it at the results. And now from the right table, we will not take again the fields because we have it already from the left table. It's gonna take only the rows and append it at the end of the table. So it's gonna take the two orders 3 and 4 and just put it beneath the table over here. And that's it. It's very simple and easy. It just needs exactly the same number of columns or fields and exactly the same data types. Alright, so now let's understand how union works in Tableau and what's gonna happen in the background once we do union. So we have here again our layers, and union is very similar to join. In the physical layer we have our tables A and B, and once we do union between them, Tableau gonna create a new combined logical table where it gonna combines the rows of both tables. And then in the visualization level, let's say that we take the field F1, Tableau gonna send a query to the data source, and data source gonna ask the logical table to get the data. And once Tableau get the data from the data source, it's gonna present it as the visualization. And as you see again here, the interaction is between the visualizations and the logical layer. Alright, so now let's see how we can do union in Tableau. We're gonna work with the two tables, orders and orders archives. Both of them has exactly the same number of fields and as well exactly the same data types. So in order to do that, we're gonna take the orders, drag and drop it on the logical layer, but you know we can do union only in the physical layer. So we have to go inside the orders, double click on it, and now we are at the physical layer. Let's take the second table, the orders archive, but now instead of dropping it at the white space, because Tableau then gonna create a join, we don't want to do that. We want to create a union. Just drag and drop it beneath the table. And as you can see, Tableau gonna say drag table to do union. So if we just place it beneath it, Tableau gonna do a union between those two tables. And as you can see, there is two lines, gray lines, indicates that there is a union. And if you want to check that, you can check at the result over here, the data. We will get a new field called table name, and you see some records comes from the orders and other records comes from the orders archives, which indicates that we have one combined table of both of the orders and the orders archive. Let's go back to the logical layer. So I'm gonna press here the X. And as you can see, we have a new icon over here. It indicates that we have a union. And as you can see, the tooltip of Tableau, it explains everything. So we have a logical table called orders. It is the result of union table, orders, and orders archive. This is one way of doing union between two tables. In Tableau, there is another way to do that. So let me show you how to do it. First, I'm just gonna remove it, drag and drop it somewhere over here. And as you can see on the left side, we have something called new union. So double click on it, and you can see we have here two options, the manual and as well the automatic. The manual, we're gonna get the result exactly like we just did. So what we can do, we can just drag and drop the tables over here, the orders and the orders archive, and then click OK. With that, we get exactly the same results without going to the physical layer and drag and drop two tables and put it exactly underneath the table. So this is a nice way to do union between two tables. You can check that by just going to the physical layer. So double click on it, and as you can see, we got exactly the same results. And here we can check the table name, we have orders, and we have the orders archive. All right, so now let's check the second option where we can do union automatically. I will go back to the logical layer and just remove the union over here. Let's start a new one from the scratch. And now we're gonna go to the automatic.
So what do we have over here? Imagine that we have around 100 tables about the orders. And this is very common if you are not working with databases, you are working with files, and the files has limitations. So what we're gonna do, we're gonna go and split the files after day, after months, after year, and so on. So we end up having a lot of files. And it is very painful if we're gonna go and drag and drop all those files in Tableau to do union, and instead of that we're gonna define for Tableau a rule, and Tableau gonna go and search for all files that follow the rule and do union between them. So what that means, for example, we have here two tables, the orders and the orders archive. What is the naming convention over here? Both of them starts with the orders. So I could have like a third table called orders underscore 2022, orders underscore 2023, and so on. So there is a rule I'm following here in my naming convention, and I can specify that in Tableau. So let's see how we can do that. So over here, the first option is gonna include or exclude. I'm gonna leave it as include, and now I'm gonna specify the rule. So it starts exactly with orders, and after this word, it doesn't matter what comes after that. It could be underscore 2022, 2023, or nothing, and so on. So anything after that doesn't matter. So what we're gonna specify after that is star. Stars means anything after orders. And then we have some options to tell Tableau where exactly to search, either at the subfolders or at the parent folders. I'm gonna leave it as it is, and then click OK. So now we have a union. Let's see what Tableau gonna say. It says we have a logical table called union, and it says we have many union table because we have the automatic way of doing that. And now let's check whether Tableau did that correct. So as you go to the right side here in the overview, you find we have a new field called path. It is the path of the files. So let's see that. I'm gonna go to the sheet one here and just drag and drop the path to see just the files. So as you can see, Tableau did it correctly. We have the orders, archive, and the orders. It's a really nice way if you have a lot of CSVs and Excels to do it automatically instead of drag and drop all those tables. Usually in my projects, I never use this because all the data is prepared in the data warehouses or in the data lake. So with that, we have learned all the different options on how we can do union in Tableau. Alright, so now let's talk about relationships. In 2020, Tableau introduced a new methods on how to combine and connect tables together, and they called it relationships. They made it even as a default methods on how to connect tables, since it is very fast and flexible. So what is relationships and how it works in Tableau? It is completely different than joins and union. If we have in the logical layer two logical tables, A and B, we can connect them at this layer using the relationships. Think of the relationships as a contract between two tables. And when Tableau uses the data from those tables, it has first to check the contract in order to understand how to generate the queries. And now it's very important to understand that once we connect the tables using relationships, the tables gonna stay separated from each others, and Tableau will not create a new logical table. So everything gonna stay as it is without any changes. And here we just describe the relationships between two tables. So now in the visualization level, if we take the field F1 from table A and F4 from table B, what's gonna happen? First, Tableau gonna check the contract in order to understand how to generate the queries, and then it's gonna send a query to the first table, and then it's gonna send another query to the table B in order to get the data for F4. And then the data gonna be combined at the visualization level and not the logical level. Alright, so now let's see how we can create relationships in Tableau. It's really easy. So we're gonna stay at the data source page and as well at the logical layer. We will not go to the physical layer, and all what we need is two tables. So let's take the orders, drag and drop it over here in the data model, and then let's take the customers. So now as you can see, as I'm moving, there is like a noodle or relationships. So let's drag it here, and Tableau gonna automatically create relationships between the orders and the customers. And now how we're gonna configure and set up the relationship. So let's go to the noodle over here and just click on it, and then there will be no new window or something for the setup. We're gonna go to the metadata over here. If you don't see the information like this, then you can go over here and you will see like the relationships and the logical tables. So make sure you are selecting the relationship. And there is like three things that we're gonna set up at the relationship. First, it's gonna be the key. It's like the join key. It is common field between the two tables. So now as you can see over here, from the left table we have the customer ID, and the right table we have the customer ID, and Tableau did automatically understand that this field could be used as a key, which is correct. But if you want to change it, you can go over here. So we will get a list of all fields on the left table, and as well you're gonna go over here, you will get all the fields from the right table, and you can add more fields for the key. Currently it is correct, so I'm gonna leave it as it is. And next we're gonna go to the performance options. So we're gonna extend the performance options over here, and we have here two things. We have the cardinality and the integrity. And if you leave it here as it is, as a default, nothing gonna go wrong. You will not lose any data, so you don't have to change anything here unless you want to optimize the performance. So what do we have over here? We have cardinality as many or one on the left side, and on the right side you can define the same stuff. For the integrity, we have some records match and or records match. So in order to understand those stuff, let's have an example. Alright, so now we're gonna have example for the cardinality in relationships. We have two tables, our orders and customers. There is a relationships between them, and the key for the relationships is the customer ID. And in the cardinalities, there is two options. Either we're gonna use many or one. And in order to decide which one is the correct one, we have to do data profiling. Data profiling means we're gonna do deep dives in the data to understand the values inside our tables. And once we do data profiling, it's very easy to select whether it's many or one. So now what those values means, many and one. There is a simple rule for that. We use many if there is duplicates in the key, and we use one if the key is unique and does not have any duplicate inside it. So now let's check the example in order to determine whether it is many or one. So let's go to the orders over here and the customer ID. You see in those values there is duplicates. We have the customer ID once here and once here as well, and the customer ID 2 is twice. So those values are not unique and contains duplicates. That's why we call it a many. Let's go to the customers over here. You can see we have the customer 1, 2, 3, and that's it. So those values are unique and there is no duplicates inside it. We don't have the customer ID 1 again in the table. So that means we can specify here a 1. So now let's go through all scenarios in order to understand what can happen in Tableau once you configure this. Alright, so now let's run the first scenario where Tableau gonna define it as a default many-to-many relationship. So we have at the left side many, and on the right side we have as well many. And let's say in the visualization level, we took the customer IDs from the order and the sum of all sales and then the name of the customer. Alright, so now let's see how Tableau gonna work. Tableau first gonna check the relationships. It's gonna say, okay, it's many to many. It's better to check the whole tables on the left and on the right. So we're gonna start on the left side. We have the customer 1. It's gonna take it over here and it's gonna sum all the sales. So since it's many, Tableau gonna understand I have to check the whole table. So Tableau gonna scan the whole table one by one. It's gonna say, okay, we have the sales 50. The next one is not the customer 1, and then go to the next. It's gonna skip it, and then we have again the customer ID number 1, and it's gonna do the sum between 50 and 30. That means we're gonna have the value of 80. It is the sum of the two sales. And now we're gonna go to the right side to find the name of the customers. It's gonna check, okay, it is many, so it's gonna scan the whole table for the customer ID 1. So now the first record, it finds, okay, we have the customer ID 1, it's gonna take Maria over here, but now Tableau will not stop. It's gonna scan the whole table since in the relationships it's many, but it doesn't make sense because the customer ID here is unique. So Tableau gonna check whether there is customer ID 1 over here and then go to the next, and then it didn't find anything, so it's gonna stay like this. And now Tableau gonna proceed with the next customer. We have the customer ID number 2. We're gonna have it as the output, and then we're gonna have the sum of all sales. So Tableau gonna scan the whole orders in order to do the sum. So we have over here the 20, and then we have here 10. So the sum of that is 30. Tableau gonna have at the output 30. So that's it for the left table. We're gonna go to the right table. Tableau gonna scan the record one by one. So the first one is not the customer ID number 2. We have here a match, so John gonna be at the output. Tableau gonna scan the whole table, so it's gonna go for the 3 and so on. And as you can see, the output is correct using the default methods of many to many, but we have here problem with that. On the right table, Tableau is doing a full scan, so with that we are losing performance on the right side. So it's better to optimize it where we're gonna tell Tableau, if you find a customer, then that's it. So you don't have to scan the whole table because we have at the maximum one record of each customers. There is no duplicates and it is unique. And now we have to tell somehow this information for Tableau. In order to do that, we can do it in the cardinality. So on the left side, it's gonna stay as many, but on the right side, we're gonna say it is 1. And with that, Tableau gonna understand, okay, it is unique. We don't have to scan the whole table and we're gonna win a lot of performance. All right, so now let's see how Tableau gonna work once we have it as many to 1. On the left side, nothing gonna change because we have many, so Tableau gonna scan the whole table. So for the customer 1, the result gonna be the same, but now on the right side, things gonna be changed. So Tableau gonna say, okay, customer ID number 1, there is a match. It's gonna take Maria as the output, but now Tableau gonna stop. Tableau will not search for the customer ID 1 and scan the whole table. So with that, Tableau will not be doing any unnecessary stuff, and we're gonna win some performance. We're gonna go now to the customer number 2 over here, same information, so Tableau gonna scan. So do we have the customer number 2 over here? No, so we jump to the next one. Yes, we have a match, we're gonna take John, but Tableau gonna stop as well and will not scan the next record. So as you can see, we have exactly the same output, whether you are using many-to-many or many-to-one. With many-to-one, we have won the performance where Tableau gonna stop the scan on the right side. Alright, so now let's jump to the next scenario where we're gonna do something wrong, where we're gonna say, okay, the customer ID on the left side is unique, and we're gonna put the value of 1. And on the right side, it doesn't matter, let's have many, for example. So now we are telling Tableau on the left side, the customer ID is unique, so you don't have to scan the whole table. And we're gonna have the same example over here. So let's see what's gonna happen on the left side. Tableau gonna start with the first customer, say, okay, customer ID 1. The sum of sales is now 50 because I don't have to scan the whole table. So it's gonna stop at the first records, and the output gonna be 50. So now on the right side, once we are saying many here, doesn't matter, the result will gonna be correct. We're gonna have Maria, but Tableau gonna scan the whole table, so the performance is gonna be bad. Now we're gonna jump to the next customer. We have the customer number 2, so Tableau gonna have it at the output, and here again the same problem. Tableau gonna say, okay, we have the sale 20, the customer ID is unique, we will not find it again in the same table, I don't have to scan the whole table. So Tableau gonna take the value 20 and gonna put it at the output without checking the other values. And here on the right side, it doesn't matter, we have John, which is correct, but it's gonna scan the whole table. So as you can see, if you make mistake here in the cardinalities, you might have some problems at the output where we're gonna have some missing data and wrong informations. Alright, so now let's run the last scenario where we have on the left side 1 and on the right side as well 1. We're gonna get exactly the same output because we have it wrong on the left side. The only good thing here is that on the right side, Tableau gonna stop the scan once it finds a match, so it will not scan the whole table. So at the output, we're gonna get exactly the same informations, and here we have 1-to-1. Alright, so now let's quickly summarize. On the left side, we have two criteria, the correctness and the performance. Correctness is always way more important than the performance. Let's start with the first scenario. We have many-to-many relationships. As you can see, the output was correct, but the performance was bad since Tableau doing unnecessary full table scan on the right side. So that's why I'm gonna give it okay for the correctness and not okay for the performance. For the next scenario, we have many-to-one relationship. The output was okay, so it was correct. We're gonna give it okay, and the performance was okay since Tableau stops the scans once it finds a match. So that's why we're gonna win a lot of performance, and we're gonna give it an okay. Let's jump to the third one. We have one-to-many relationships. As you can see, the output was not okay. This was not correct. We are missing data, so we're gonna give it not correct, and the performance was bad because on the right side we are doing unnecessary scans. So that means it was the worst scenario over here. And then the last one, we have one-to-one relationship. The output was not correct and not okay, but the performance was okay since on the right side we are not doing any unnecessary scans. But to be honest, correctness is way more important than the performance, and that's why Tableau always recommend to stay at many-to-many relationships if you are not sure, because you're always gonna get correct answers at the output, but if your data is big, you will get some bad performance. So if you want to have like good performance, you have to invest time in analyzing your data, doing data profiling to understand, is it many, is it one, and then change it. But you have to be sure about your data, otherwise you will get wrong informations at your visualizations, and that's really bad. So that means for this example, the safe way to do it to stay at many-to-many relationships, but the professional one is to have many-to-one relationships to get good performance. But this is not always the scenario. Just imagine we switch the tables between customers and orders, so customers is left and orders is right, then one-to-many relationships is gonna be the correct one. So be careful here with the sides.
Alright everyone, so now let's understand the integrity options in Tableau. Each relationship has two sides, the left table and the right table. When we are changing the settings of the integrity, we limit which joins can happen in the visualization. So here we have two options, some record match and all record match. And with that we have four scenarios. First, we can choose some record match in both left and right tables. And if we do that, then all types of joins are possible in the visualization. We have inner, left, right, and full join. But now if we choose all record match on the left and some record match on the right, So what can happen now, we are limiting the types of joins to only 2 types, inner and right join. And the next one is going to be the opposite, so we have some record match on the left and all record match on the right. What can happen, again here we limit the types of joins to only 2 types, the inner and left join. And in the last scenario, if we choose all record match on both sides, the left and the right, then here we limit Tableau to only 1 type of join, the inner join. So as you can see, it's very similar to joins, we are just defining how Tableau should work. When we use some record match, we allow more types of joins, and when we use the option or record match, then we are limiting Tableau with the types of join. And here it's very important to understand that we have a trade-off. If you use or record match and go down this path, you will likely experience better performance, but you will increase the risk of losing data. But if you choose to use some record match and you go up, you will ensure the completeness and the flexibility, but you are sacrificing some resources and performance. And Tableau team here decided to go with the first scenario, where you have on the left and the right some record match. And I can understand that because it's more important to have completeness and flexibility more than performance. Let's have a look at our data. So here we have customers that didn't order anything. So the customer number 3 didn't order anything over here and we don't have a match of it. So we can say some records matches, like the 1 and 2 are matching on the left sides, but some other records does not match. So we don't have an order from the customer ID number 3. So that means in our database, we could have customers in the customer table that didn't order anything. So the correct option over here is some records matches. Now let's analyze the orders. As you can see, we have the customer ID number 1, we found it in the customers, 2 as well, and so on. So we can say that all the records or all the customers' IDs in the orders has a match from the customers. Well, that means we can select all records match. We don't have, for example, customer ID 4 over here, which does not have a match on the right sides. So that means in our database, all orders should come from our customers and we should not have any order without a known customer. So after the analysis, we can say on the left sides on the orders, we have always a matching record. So we're gonna select all records matches, but on the right sides, we might have customers that didn't order anything. Then we can say some records matches. If we do it like this, we can prevent Tableau from doing any extra stuff by analyzing the nulls. Like in SQL, if you have full outer join, you will get like huge amount of data, and sometimes if you're using inner join or left join and so on, you will get better performance. So if you know exactly what is going on in your data, then select the correct integrity. Otherwise, just leave it as a default. Some records matches on the left and on the right, you will be safe, you will get correct answers. Alright, so now back to Tableau. Relationships are really easy. We just have to drag those 2 tables and Tableau can create relationships between them. Just get the key between the relationships correct and everything gonna be fine, and leave those stuff as a default. But if you want to be like more professional and get better performance in Tableau, you have to do data profiling and then select the correct one if you are 100% sure. So in this example, the orders over here has many in the customer IDs, but we have on the right side 1 for the customers, and then for the integrity on the orders or records matches, because all orders has a customer ID in the customers table, but we might have some customers that didn't order anything, so I'm gonna leave it as some records matches, and that's it. That is relationships in Tableau. Alright, so now let's talk about data blending in Tableau, but first some coffee. Let's go. Alright, so now let's have this example where we have in the data source table A, and now in the visualization level, we want to use the data from the field F1. And you know by now, Tableau gonna send a query to the data source in order to get the data of the F1 from the table to show it in the visualization. And now since this data source was the first one to be queried and to be used, and Tableau gonna call it a primary data source, and in Tableau anything is primary gonna get the blue color. That's why you will see like blue icon indicates that this data source
source is a primary one. And now sometimes we are in a situation where we want to get the data from another data source. For example, we have another data source with a table B, and we want to add the visualizations to show the data of F4. So what's gonna happen? Tableau gonna send another query to the second data source in order to get the data of F4, and then the data can be forwarded to the visualizations. And here Tableau gonna call this data source as a secondary data source, and it will mark it with an orange icon. And now in order for this to work, where we're gonna get data from two different data sources, we have somehow to connect them. And here exactly we're gonna use the very unique way in Tableau where we can connect data sources together using the data blending. And data blending can only be done at the visualization level on the worksheet page, not in the data source. So now you might ask how Tableau is joining those tables at the visualization level. Well, Tableau is using a left join. We cannot change that, sadly, it is fixed. Since it's like a left join, Tableau gonna get all the data from the primary data source and only the matching records from the secondary data source. So now to summarize, data blending is the method of combining data at the visualization levels from two different data sources using a left join. And this is a very unique feature in Tableau. You don't find it in any other BI tool like Microsoft Power BI. You cannot, for example, there combine data from two different published datasets. Alright, so now let's see how we can do data blending in Tableau, and for this we need two data sources. The first one gonna be from the CSV files that we have from the small data sets. So we're gonna go to the text files and let's take the products over here. So this is our first data source, and now let's go and create the second data source. In order to do that, you can go to this icon over here and then click on new data source. So let's go there. It's gonna be from the JSON file that I prepared for you. So let's go to JSON, and we have the product prices. So let's open that. Since it's JSON, we have to select the schema. So let's go to the data over here and click yes, and then click OK. So now we have two data sources. In order to switch between them, we go again to this icon over here, and you can see we have now two data sources, and by just selecting the data source, you will switch to it. And now in order to do the data blending and to connect those two data sources, we cannot do it at the data source page. We have to go to the visualization level to the worksheet page. So let's do that. I'm gonna go to the sheet one over here, and as you can see at the data pane on the left side, we have two data sources, and by just clicking on them you can switch in order to see the tables inside them. So now we have to decide which data source is the primary and which one is the secondary. For this example, I will say that the product is the primary one. And how we're gonna do that? By just using the data in the visualizations as the first data source. So I'm just gonna take the product ID, drag and drop it on the rows, and immediately Tableau gonna understand, okay, this is the primary data source, and it's gonna mark it with a blue icon over here, indicating that this is our primary data source. We still don't have a secondary data source, so you see there is no orange icon over here, because in our view we have data only from one data source. So now in order to get the data from the second data source, we're gonna switch to the product prices, and you can see Tableau immediately turn this data source as a secondary data source. So you can see over here we have the orange icon indicating that this is secondary data source, and any field that we are using, it's gonna mark it with orange. So you can see over here the price, it has an orange icon. So that's it, it's very simple. So now let's say that the product ID is not the key of order to join those two data sources. You want to change that. In order to do that, we're gonna go to the data over here in the menu, and then go to the edit blend relationships. Let's click on that. We will get a new window over here, and here we have two options, automatic and custom. If you leave it as automatic, Tableau gonna figure out which key to join those data sources, and here in this example is the product ID. But if you want to change that, you can go to the custom over here. It's like join, you have to specify from the left and from the right which fields are the key in order to do the join. So if you want to change that, just double click on it, and then you have on the left side the primary data source and the right side the secondary data source, and then you select the fields that are the key for the join. So I'm gonna leave it as it is, and let's add another key. So I will go over here and add, for example, the category is from the left side, and from the right side the data index, which is really wrong. So let's click OK, and then again OK. You will see on the left side now we have another chain on the data index, and you can see it's like broken chain. So that means it is not yet used in the join. If you want to activate it, just click on it, and you will see we have an active chain. And now as you can see, the result is wrong because it doesn't make sense to use this key, but I just want to show you how you can deactivate and activate the key of the join between two data sources by just clicking on them. So now let's just correct this. I want to have only the product ID as the key for the join, so that means I'm going to deactivate the data index over here, and that's it. This is how you can define the key for the data blending. And now one thing that is very important to understand is that everything that we've done in the data blending is only relevant for this worksheet. So if I go to another worksheet, let's go over here and create a new one. And now as you can see over here, it's completely resets. The two data source, we have it again, but we don't have it as primary and secondary data sources. That means in each worksheet, we can make a new decision. So at the sheet number 1, the products were the primary. I can change my mind here where I can say, okay, the product prices now is the primary data source. So if I take anything over here, you can see product prices is the primary. And if I go to the products and let's say I'm going to take the product name over here, product's going to be the secondary. So I just switched between them depending on the requirements. So if we go back to the sheet number 1, we see that the product is the primary. But if we go to the sheet number 2, the product prices now is the primary. This is really nice because it gives us really flexibility where we can decide in each worksheet which one is the primary and which one is the secondary depending on our requirements. So data blending is very unique and great way on how to connect and combine data. Alright, so now what is the main difference between joins and unions? Both of them are very similar. They're gonna combine two tables in one big table, but the difference here is that's how the data gonna be combined. In joins, the fields of both tables gonna be combined. So we're gonna take all the fields from the left side and beside it all the fields from the right sides. So the result, we're gonna get one big wild table. But in the other hand, in the unions, two tables gonna be combined, but instead of combining the fields, here we're gonna combine the rows of both tables. So we will get all the rows from the first table and beneath it all the rows from the right table. But both of them has exactly the same columns. So joins combines the fields and union combines the rows.
Alright, so that was the main difference between join and union.
Alright, so now the question is, what is the main difference between joins and data blending? Data blending is like a left join, but the main difference here is that when the aggregation is gonna be performed. In joins, the data gonna combine first and then the aggregation gonna happen, but in data blending is exactly the opposite. The aggregation gonna happen first and then the data gonna be combined. So now let's have a simple example in order to understand what this means. Okay, so again we have our tables, customers and orders. First we're gonna do the left join and afterward we're gonna do the data blending between them in order to understand the differences between them in the output. Alright, so now we're gonna start with the left join. You know left join, all the data from the left sides and only the matching on the right side. So we start as usual by combining the fields from left, the fields from right, and we start record by record. So we're gonna take the customer number 1 and we're gonna search for the matches. We have 2 rows on the orders, so that means Maria gonna be twice in the output because there is 2 orders. And then we're gonna go to the next one, customer ID number 2. We have only 1 order for that. We're gonna have it at the output, and George don't have any orders, so that means we're gonna have nulls. Null here, here and here. So as you can see with the left join, first we combine the data, the raw data, without doing any aggregations, and afterward in the visualizations we can find, for example, the sum of sales or the average and so on. And now let's check the data blending, how it works. Alright, so now let's say we have all the fields from the primary data source and beside it all the fields from the secondary data source. And this is like left join, we're gonna take all the data from the primary data source. So we're gonna get all the 3 customers over here, but the main difference here is that there will be no duplicates. As you can see, we have here Maria twice, but in data blending, you will not get any duplicates. And now here comes the difference. Before we start getting the data from the orders from the secondary data source, an aggregation gonna happen. So for example, with the customer ID number 1, we have 2 rows. The 2 rows will not be presented at the output. First, it's gonna be like an aggregation. And now it's very important to understand that the fields in Tableau are split between dimensions and measures. In the next tutorials, I'm gonna explain that in details, but now the measures can be aggregated, the dimensions will not be aggregated. So for example, the customer ID, it is not a measure, it is a dimension, so Tableau cannot aggregate it, but since we have it twice the same value, Tableau gonna write here 1. And then the next one, we have the sales, it is measure, so Tableau gonna aggregate first and then combine it. So the sum of that's gonna be 80, so let's do that. And the next one, we have the date. So here it is a dimension, cannot be like aggregated. And since we have two different values, Tableau gonna write at the output a star. And since Tableau gonna provide at the output only one value, and we have here two values, Tableau will not decide which one of them gonna be, so Tableau gonna add a star. So what's gonna happen in the output gonna be star. I know this is really not nice, but this is how data blending works. So as you can see, Tableau always try to aggregate the data before combine it. Now let's move to the next customer. We have John, and in the orders we have only one record. That means nothing gonna be aggregated. The output gonna be exactly the same. And then for the customer George, there is no information over here. We will get as well nulls. And this is the output of data blending. And this is exactly what I mean with the main differences between joins and blending is when we do the aggregations. So in the left join, as you can see, first we combine the raw data together, and afterward we can do aggregations in the visualizations. But in data blending, first the data should be aggregated, especially from the secondary data source, and afterwards the data gonna be combined in Tableau. Alright, so now what are the main differences between joins and relationships? If you are using joins, things gonna get really static and we might lose as well a lot of data. But if you are using relationships in our data model, then we will get more flexibility and we will not lose any data. And now in order to understand this, let's check this example where I have prepared two data sources, one with joins and the other with relationships. The first one with the orders, if I go to the physical layer, you can see we have a left join between orders and customers. And let's check the second one, we have the relationships. We have as well the same tables, we have orders and customers. And between them there is a relationship. And now if we check our data, we can find that there is 5 customers. And in the orders, there is only 4 customers that did order. So if you check over here the customer ID, you will not find the ID number 5. So that means this customer didn't order anything. This is no problem for the relationships, but if you go to the joins over here, and you check the data, you will see that we don't have a customer ID number 5 at all in our data. So you can check, okay, we have 1, 2, 3, 4, and so on. So the customer ID number 5 is completely disappeared. And that's because we have a left join between the orders and the customers. So only the matching rows from the right side is going to be presented at the final table. So that means we lost this customer. And if we are at the visualizations, let's go over here. And let's say we want to count how many customers do we have in our database. So let's drag and drop the customer ID and let's turn it to a measure of count distinct. So our data says, okay, we have 4 customers. If we go to the relationships, let's open another one and switch to the relationships. And let's take the customer ID again over here, switch it to a measure and count distinct. You will see we didn't lose the data. We have 5 customers in our database and the relationship is going to give us more correct answers. And now you might say, okay, we can fix this if we change the type of join. So that's right. If I go to the data source and then I go to the joins, go to the orders, and I just switch this to the right. So that means we're going to get all the data from customers and only matching from the orders. Let's close this and go back to our sheet number 1. You will see, let me close this. You will see that we have 5 customers. So with that, we have correct answer as well as with the join. And here we come to the next point that things are really not flexible. So that means if I'm building visualizations where sometimes I'm asking how many customers do we have or how many orders do we have, I cannot each time go to the data source and change the type of join. Because once I decide it's a left join, it's going to stay for all the worksheets as a left join. Unless I'm doing full outer join between the 2 tables. And if you are working with big tables, then you will get a very big merge table, which gonna slows everything down. And this is exactly what I mean. If you are using joins, you will lose data if you are using left join or right join. And as well, things are really static. With the relationships, if we go to the sheet number 2, here things are more flexible because we didn't merge anything. The data stayed separated from each other's. We just described the relationships between them. So if in worksheets I'm doing analysis about the customers, it will not affect the next visualizations if I'm doing analysis about the orders, because we didn't lose any data. And I don't have to worry, do we have left join or right join, should we change it, and so on. So it's more flexible and we will get always a correct answers. So that's why joins are static and you might lose data, but relationships are more flexible and you will not lose any data. Alright,
Alright guys, so there is another issue with the joins if you compare to the relationships. Sometimes in joins we might get wrong answers if we are doing calculations on the measures. So let's take this example. On the customers tables we have the score, so for each customers we have a score, and we have those 5 customers. The average of this score is gonna be 625. And now let's check in Tableau the results from joins and relationships. Alright, so now we are at the relationships and let's take the score and drop it over here on the text, and then let's find the average. So we're gonna go over here, measures, and the average. So in relationships we got the correct answer, we have 625. And now let's check the joins. We are at the data source of joins. I'm gonna take the score, drag and drop it on the text, and now we're gonna switch as well to average. And here we got the wrong result, 585. So what happened here? Well, the answer for that is sometimes if we merge 2 tables together, we might get duplicates. So let's check the data. If you go to the data source again, in the joins, if you go to the score, we will have duplicates because some customers have more than one order, and that's gonna result in a lot of duplicates if we merge the customers and orders. And if you do the average, you will get the wrong answer as we saw in the results. And if we switch to the relationships and we go to the customers, we see at the score over here on the right side, there is no duplicates and we will get the correct answer. And that's gonna guarantee for us that using relationships, we will get correct answers if we are doing calculations. And that's way better than having duplicate in our data. We might never get correct answers from joins. And that's why Tableau introduced in 2022 relationships just to fix all those problems with the joins. And they made it as the default method on how to connect tables. Alright guys, so now we're gonna go and compare the 4 methods on how to combine data in Tableau: unions, joins, relationships, and data blending side by side. So let's go. The first point is in which page, in which layer we can use the method. Now both union and joins, we can create them at the data source page in the physical layer. And as well the relationship, we can use it at the data source page, but in the logical layer. And finally, the data blending could be used at the visualization level in the worksheet page. And the next point, can we use the method in order to connect tables from different data sources? Well, for union, joins, and relationships, we cannot do that. It should be done in the same data source. But only the data blending could be used in order to connect tables from different data sources. The next point is, after using the methods, are the tables going to be merged? In unions and joins, they're going to merge the tables and they're going to create completely new tables. But if you are using relationships and data blending, they will not create anything. The next point is about the flexibility. If you are going to use unions and joins, the decisions that you are making at the data source going to affect all the worksheets and the visualizations. But if you are using relationships and data blending, you have way more flexibility. For example, in the data blending, you can decide on each worksheet page. Now, if you are talking about the join types, in joins we have inner, left, right, and full. In the relationships, we can have as well exactly the same behavior as joins. But in data blending, it is fixed. We have only left join. And the next point, if you ask me to rank these methods, I would say, and Tableau as well gonna say, always use relationships. And after that comes the data blending. It is really great way on how to combine tables from different data sources and the flexibility that we have. And then the third one, I'm gonna say the joins. I would not rank union because it's completely different than the methods of joining, relationships, and data blending. So always try to go with the relationships. And now let's see the big picture on how those 4 methods works. And let's start with joins. They're gonna connect 2 tables at the physical layer and they're gonna create completely new logical table in the logical layer where it's gonna combine the fields of both tables. And then at the visualization layer, the dataset is gonna create a query at the data source and data source gonna get the data from the logical table. And same thing for the union, you can create it at the physical layer of 2 tables and they're gonna create as well completely new table where the rows of both tables gonna be combined. And at the visualization, Tableau gonna send a query to the data source and the data source gonna get the data from the logical layer. And now to the third method of the relationships, we have 2 tables at the logical layer and Tableau will not combine or create anything. We are just describing the relationship between A and B. And at the visualization level, Tableau gonna ask the data source and the data source gonna get the data from the separate tables. And finally, the data blending, we have 2 data sources. The first one gonna be called the primary data source. The second one is the secondary data source. So first, Tableau gonna send a query to the primary data source and then another query to the secondary data source. Here it's important that the aggregation gonna happen before the data is combined, and we are combining the data at the visualization level using data blending. So as you can see, joins and union happen in the physical layer. In the logical layer, we can do relationships,
And at the visualization level, we can do data blending. Alright guys, so now we're going to create together two data sources because we have two data sets, the big one and the small one. And during that, I want to show you how I usually make decisions on when to use which methods. So let's go. Okay guys, so now let's close everything and start from the scratch in order to get the data source correctly created. So let's start Tableau public. We're going to create now the small data source on top of our small data set. So let's go to the connectors on the left side and click on text file. And then it doesn't matter which one you're going to use. Let's take the orders, open. I will delete it anyway in order to explain how I start. So previously I showed you the data model of our datasets. We have a star schema where we have facts and dimensions. I always start with the fact table. Doesn't matter whether you are using star schema or Snowflake, always start with the fact table. So our fact table is orders. So let's just drag and drop it here on the logical layer. And then I continue with the dimensions. So we have customers and products. So let's start with the customers. Just drag and drop somewhere over here. And Tableau gonna create a relationship between the orders and customers. And since we are talking about two different entities, so we have orders and customers, I always use relationships between them. And now let's check the relationships whether everything is correct. So we go over here on the metadata. We see the customer ID from left, the customer ID from right, which is correct. And now let's go to the performance options. I will change only the cardinality. If the quality of our data is bad and we haven't done any data profiling, then the best is to leave it as default. So many to many, some record matches on the left and on the right. But in the datasets, we already checked that, so we have clean star schema, and always on the fact side, on the left side over here, it's gonna stay as many. And all the dimensions on the right side, like customers, it's gonna be 1, because we have usually, for example, unique customers or unique products. So I will go and change that on the right side as 1, because it is dimension side, and on the fact side, it's gonna stay as many. I will not touch those integrity stuff, so we're gonna leave it as it is. And that's it. We have now the customers and the orders connected to each other.
And now before we continue building our data model, we have to check something very important. Are we working on the correct datasets in the correct format? So now if you go to the orders over here, and here we have some few fields like the sales, quantity, discount, profits, all those informations should be in number. And you can check that by checking the icons, the data type icons. And if they are like this hash value over here and green, if you click on it, Tableau gonna say it is number decimal. So if you see it like this, a number decimal or number, then everything is fine. But if you see it as a string, for example, if you go over here and switch it to string, so if you see this field as a string, there is something wrong. So if your data is like ABC, then you are working with the wrong datasets. It's not correct. So you should see it like a number. So now the question is why it's wrong, why it's not correct, why Tableau didn't find it as a number. Well, there is different representations of the decimal separator in decimal numbers. Some countries like in Europe, we have a comma. But in many other countries like in USA, in Asia, we have a dot between the decimal number and the whole number. So now for example, I'm now in Germany and my data is separated with a dot. What's gonna happen? Tableau will not understand this is a decimal number and it's gonna show it as a string. And that's why in the download link, I have prepared two datasets depend on your location. The Europe training datasets and the non-Europe training datasets. The Europe training datasets, all decimal numbers are separated with comma, and for all other countries, they are separated with a dot for the first downloader. So now the question is how to fix it? Well, go and download the correct training dataset. There is another way in order to fix it. For example, now I have the non-Europe datasets, and as you can see, the discount, sales, profit, everything is wrong, everything EPC and string. Now some of you think, okay, it's really easy fix. I can go to the data type over here and switch it from string to a number decimal. So once I do that, what's gonna happen? Everything gonna be null. So it will not work because Tableau don't know how to convert those numbers correctly. So let's move it back to a string in order to see the data again. There is a fix for that. If you go to the orders over here and then right click on it, and let's go to the text file properties. So here we have different properties about the files like the separator. Here we have it semicolon, so Tableau did detect it correctly. But what's more important than this is the format of the decimal number, the locale. So here we have to choose a locale which is matching to the current format. So the current format is a dot here in this example. So what we're going to do, we're going to go over here and search for example, United States. And as you can see, Tableau gonna understand the correct format and everything gonna be changed to a number. So the solution, either you're gonna use the correct datasets or you can go and configure the properties of each file. So I would say you can go and try United States or Germany until you have the data type number. So make sure that in the orders, all those informations is the data type number. Alright, so now let's go and keep building our data model in the data source. Let's go to the next dimension. We have the products. So all what we're gonna do is just drag and drop and then release it. Tableau gonna create another relationship between them. Let's check that again. So click on that, go to the metadata, scroll up. So Tableau did automatically find the key for the relationship. It is the product ID, which is correct. And now the same thing, we're gonna go to the performance options. On the left side, on the fact side, it's gonna stay as many, and on the right side, it's gonna be 1. So on the right side, we have the dimension, it's gonna be 1. You can check that easily if you click on the products, and here check the data. You can see the product ID is a unique field, there is no duplicate inside it, and we can go and use 1. If you are not sure, just leave it as many to many relationship. So let's go again to the relationship. We have it many to 1, and I'm gonna leave it here as some records matches, no problem. And now let's go to the other tables. We have here the customers details. And here we have two options. Either we're gonna use relationships or joins. So you can go over here and just drag and drop, put it near the customers as a relationship. But to be honest, in data modeling, if I have two objects about the same entity, so here we have customers and here another informations about the customers, I tend to merge those two tables in one. This is different than talking about the orders and customers. They are completely different entities. And usually in data warehouses, I prepare this step in the database. Or we can stay on Tableau and merge those two tables into one. And we can do that using joins. So what I'm gonna do, I'm just gonna remove the customers details away. And then we're gonna go to the physical layer inside the customers. And then we're gonna take the customers details and drop it over here. And Tableau as default gonna leave it as inner join, but to be honest, the customers table is for me the main table about the customers, and customer details is like secondary table. So in order to not lose anything from the left side, I'm gonna change the type of join to left join. So let's do that. I'm gonna click on the icon and then select left join. Then we can check the results. Well, the main thing that we don't get duplicates or we don't lose any customers. So as you can see the output, we have our 5 customers, there is no duplicates and we didn't lose anything. So let's go back to the logical layer. I'm just gonna close this. So as you can see, we have list tables and we have one entity called customers. We don't have a lot of tables, and I usually do that if we have a lot of tables about the same topic. And now let's go to the next table. We have the order archive. And here we have the same situation. We have 2 tables describing the same entity, the orders. But of course we can connect it as relationships to the orders. But again, I like to minimize the number of tables that I'm dealing with, and I'm gonna go and merge those 2 tables together. And so here we have again 2 options, unions or joins. If the tables has exactly the same number of columns and the same data types, then we can use union. In order to do that, we have to do data profiling. So either you open the CSV files and compare them together, or we can go over here. There is like a small icon like a table, and if you click on it, Tableau gonna show you a sample of data in order to do data profiling and to understand the content of this table. So let's just make it bigger. So we have the order date, shipping date, customer ID, product ID, and as well the unit price and so on, and we can compare it to the orders over here. And let's just make it bigger, and we can find exactly the same number of fields, the same content, the same data types. So that means we can go and do union between them. So in order to do that, I'm just gonna close this and go to the physical layer inside the orders. I like to drag and drop just beneath it over here. And now you can see we have a union. Let's check that on the right side in the table name. So we have orders and we have orders archive. So with that, we combined both of the tables in one logical table. So let's close this. And as you can see, we have the icon that there is inside it a union. And with that, we have only 3 tables instead of having 5 tables. It is just easier at the visualizations to deal with 3 tables instead of 5 tables. And the data model is much easier to understand and to explain. And with that, we have connected all the CSV files together, but we still have one file, the JSON file, product prices. Sadly, we cannot connect it with the others in the same data source because it is different file type, but we still can connect it to them if we create a second data source and use data blending. And now that's it. So we have our fact table and the dimension. We're gonna give it a name. So I'm gonna call it small data source. And now you can pause the video and go and create the big data source.
And if we are done, I'm gonna go and create the big data source. So I'm gonna go over here, new data source, gonna click on the text file. Then I will just go back to the big one. Here we have only the 3. So we start with the orders. Always we start with the fact table, and then we take the dimensions. Let's take the customers. Customers, I already checked all those IDs. They are unique, so I can go to the relationships over here and change it to 1 on the right side. And on the fact side, it's gonna stay as many. The same we're gonna do for the products, drag and drop. And all the IDs of the products are unique, so we can go to the performance option just to make sure we select the relationship and select 1. So that's it. So I'm just gonna call it big data source. So now in order not to lose those data sources, in Tableau Public, we have to publish to our public account. So I will go and do that. We're gonna go to the sheet over here, and let's just take something like the customers, drag and drop on the rows, and that's it. I will just go over here and publish it. Save to Tableau Public. And I have to sign in. I'm gonna call it data sources, then save. And now it starts publishing to our profile. So that's it. If you want to download the file, you can go over here and download Tableau Workbook. Alright guys, so with that we have created 2 data sources on top of our datasets, and we're gonna use them in the whole tutorial.
Alright guys, so with that you have learned everything about the Tableau data modeling in data sources and how to combine tables using the 4 methods. And in the next section we will start talking about the metadata in Tableau. We will learn there many important Tableau concepts for data visualizations. The metadata of Tableau. Understanding the Tableau metadata concepts like data types, measures, dimensions, discrete, continuous is very important in order to build a correct data visualizations in Tableau, and as well can help you to understand how Tableau works with your data. So first I'm gonna introduce you to the metadata in Tableau to learn what happens to your data once you connect it to Tableau. Next we're gonna dive into all data types in Tableau like integer, string, date, and so on. And after that we're gonna learn about the data type rules like the geographic rule and the image rule. And after that, we're going to cover very important concepts in Tableau. We have dimensions, measures, discrete, and continuous. And of course, in order to understand the differences between them, we're going to compare them side by side in order to understand the big picture. So now let's start with the first topic where we can have an overview of the basic concepts of metadata in Tableau. So now let's go. Alright, so now we're gonna have a quick introduction to the Tableau metadata in the data sources in order to understand what's gonna happen to our data once we connect it to Tableau. After connecting our data to Tableau and building the data model in the data sources, the next step is to check the metadata of the tables and the fields. Because once you connect your data to Tableau, Tableau gonna start analyzing the content of your data to make assumptions about the types and roles of each field in the data source. So Tableau can assign each field to data types like integer, string, date, and so on. Data types gives us information about the kind of data stored inside our datasets. This piece of information is very helpful for Tableau in order to understand how to deal with your data, which rules, operations, calculations can be performed. And one more thing that Tableau gonna do, it's gonna assign each field to a role. These roles gonna help Tableau building the visualizations. So the first set of roles, we have dimensions and measures. Dimension fields define the level of details of the view, and the fields with the role measure gonna be used for aggregations in the view. And we have another set of roles, we have discrete and continuous. These rules can help Tableau by plotting the visuals. So discrete fields gonna break the view to separate values, and the fields with the continuous rules gonna plot unbroken chain and connected values in the view. And I call all those informations about your field as a metadata in the Tableau data source. One more thing that I want to tell you is that those assumptions that Tableau makes about your field is correct around 90%. So that means there is a possibility that those assumptions from Tableau are wrong. That's why it's very important after you build the data model is to have a double check on the metadata to check that all the informations are assigned correctly. Otherwise, you're gonna have bad quality and bad results at the visualizations. Alright, so next we're gonna do a deep dive into these important concepts in order to understand them and the differences between them. Alright, so we can find data types not only in Tableau, but in all programming languages, but they don't support exactly the same data types. And that's why if you are learning a new programming language or an application like Tableau, it's very important to understand which data types they support. And now the question is, what is a data type? The data type gives us information about the kind of information stored inside our data. And this piece of information is very important for programming languages and applications like Tableau in order to understand how to deal with your data, which rules, operations, and calculations could be performed on top of your data. Now, if you look closely to our data, you can see that each field in our data source must be assigned to a small icon or a symbol. Those icons indicate the data types of each field. And now one more thing, once we connect our data to Tableau, Tableau can analyze our data in order to assign automatically the correct data type to our fields. Well, most of the times Tableau does it correctly, but sometimes things goes wrong or you want to change the data type of specific field. This is really easy. Either you can do it on the worksheet page or at the data source page, you will get exactly the same effect. So let's go to the data source page and let's go to the orders and click on the icon over here. You can see it's number whole. We can change it to a string. So what we're gonna do, we're just gonna click on the string and that's it. We just changed the data type of the order ID. But let's say we want to change it back as Tableau did it at the start. What we're gonna do, we're gonna go to the icon over here again, and then we go to the default. And it's back to the original data type that Tableau did assign at the start. And here one more thing to notice is that the data types are really sensitive in the joins and the relationships. For example, if we go to this relationship over here between the orders and the customers, the key is the customer ID. Those keys should have exactly the same data type. So let's say we go to the orders, and let's change the customer ID from number to string. So we're gonna go to the string over here and we change it. And immediately you can see at the data model, the relationship between the orders and customers is now broken. And you can see at the tooltip, it's gonna say type mismatch between the customer ID, the string, and the customer ID number. So as you can see now, Tableau is very sensitive with the data type of the key. Whether you are using relationships, joins, data blending, doesn't matter. They should have exactly the same data type. So now in order to correct it, as you can see, we don't have anymore the data preview, the data grid. So how we can change now the data type, we're gonna go to the metadata grid and we're gonna do the same thing. We're gonna go to the customer ID, just click on the data type icon and change it back to default or to number. So I'm just gonna click on default and Tableau gonna be happy now and the tables are related again. And the third way to change the data types, you can go to the worksheet page and same thing over here, you can go to the icons and change the data type. So as you can see, it's really easy. In Tableau, we have a bunch of different data types that we're gonna cover in this tutorial, and I group them into 3 categories. First, we have basic main 6 data types. We have the number whole, number decimal, string, date and time, and boolean. And the second group, we have roles, we have geographic roles and image roles. And the last group, we have advanced data types like group, cluster group, bins, and set. And this group contains special data types that's introduced from Tableau for data visualizations, and they are specially made in order to organize our data. In this tutorial, we're gonna focus on the first 2 groups, the basic and the role. And for the advanced data types, I'm gonna dedicate another full tutorial just speaking about them. Alright, so now let's start with the first group, the basic data types, where we're gonna do deep dives into each type in order to understand them. So let's go. Alright, so now we're gonna talk about the data type number. If our data contains only number, nothing else, it contains digits from 0 to 9, then we can call it a number data type. And it's very important to understand that numbers cannot contain any characters. For example, let's say that we have the following phone number in our data. This type of data, we cannot call it a number because it contains characters, like we have the minus, we have the plus, because the number data type can only have digits from 0 to 9. And now if we remove those characters from the phone number, then it's gonna look like this, and only now we can give it the data type number. And in Tableau, the data type number has this icon, it's like a hash. And for numbers, we have 2 data types in Tableau. We have number whole and number decimal. So what is the difference between them? You know, in math, a positive or negative number could be splitted by dots. The first part, we call it a whole number, and the second part, we call it a decimal. So if your numbers does not include decimal dots or any fractions, then we can call it a whole number. like 3, -100, 0, and so on. But if your number contains dots and fractions, then we call it a decimal number, like 2.4 or 30.99. And here you need to be careful which one you are using, especially if you are making calculations in Tableau. For example, if you want to divide two numbers, like 1 divided by 2, if the output field has the data type whole number, then the result gonna be 0. But if it has the data type number decimal, then the result gonna be correct, 0.5. And this is exactly the difference between those two data types. Alright, so now let's check our fields in Tableau to find out which one has the data type number. And I would say let's check the orders over here, and you can see we have the order ID, customer ID, product ID. By just checking them, you can find that all of them are numbers, they don't have characters, and they don't have fractions. So that means they should have the data type number whole. As you can see, all of them is number whole. Let's check another fields. On the right side, we have here sales, we have discount, profit, and as you can see, they have fractions. So those numbers should be a number decimal. So let's check that. You can see Tableau did automatically figure out that those numbers are number decimal. But for the quantity, it's whole because we don't have here any fractions. So that's it, everything is fine. Alright, now we're gonna talk about the data type string. The string data type is one of the most widely used data type in all programming languages. A string data type is a sequence of characters, and it could include anything, like letters, numbers, spaces, and any other type of characters. And you can think of a string as a plain text. And any field in our data source could be a string. So string is like a default data type, and it has no rules or whatever like the other data types. So that means you can convert any fields in your data source to a string data type without any problem. And Tableau as well uses the string data type when it couldn't find any suitable other data type for your fields. So now let's check in our datasets where we can find fields with the data type string. So let's check first the products over here. You can see we have here two strings, the product name and the category. In the product name, we have characters, we have spaces, we have numbers. So those are the data type string. Let's check the customers over here. We have the first name, last name, both of them are string. But now you might notice or ask, you know what, we have city and country, both of them contains like characters. Why don't we have the icon of ABC? Is it like string? Well, the answer is yes, because if you just click on the icon, you can see that Tableau did assign it to a string. But here the difference is that they have an extra role. We have the geographical role, and you can see Tableau did assign it to a country. And here Tableau gonna give it another icon just to indicate that this field has a geographic role, but the main data type for that is a string. And the same is for the city. Okay, now we're gonna talk about one of the most confusing data type. It is the date. If your field stores information about the calendar data, then this field is gonna have the data type date. And dates have very different formats in different countries. For example, in Germany, we have the following date format. You see, we use dots instead of slashes. But date in the international formats follow another rule where the date gonna split it by a minus. And in the world, there are many different formats. So those dates follow specific formats, and we describe it with the following code. For example, for the international formats, we have this code. It's gonna start with the year, and the year had 4 digits. That's why we have 4 times Y. Then we have a minus and 2 digits for the months. So we have MM minus 2 digits for the day, DD. So there is like a code for each part of the date. We have the day, months, year, weeks, and so on. In this table, I'm gonna leave the link on the description. You can find all those codes and the descriptions of that. So with that, you can customize the date format as it suits you. And don't worry about it, Tableau understands almost all date formats that we have. And in our data, we could have not only the calendar data, but also information about the time. Then we have in Tableau another data type for that. We call it date and time. And in programming languages or databases, you might heard already about the timestamp. But in Tableau, we call it date and time. So it might look like this. We have the date, then space, and then afterwards, we have information about the hour, the minute, and the seconds. And like the dates, it could have as well different formats. You could have the milliseconds or the time zone and many other stuff. So here we have again a table of all the codes for the time informations. You can find it as well on the same link. Alright, so now let's check our data to find out which fields has the data type date. Usually in a star schema data model, all the dates are placed at the fact table. And our fact table is the orders. So let's check that. You can see we have 2 fields with the data type icon dates. We have the shipping date and the order date. And it's not date and time because we don't have in the data information about the time. So both fields are dates. We can check here and as well here.
And in the other tables, products and customers, they don't have any dates or times because they are dimensions, they are not events, and usually don't have any information about the date. Alright, so now let's go back to our orders, to our two fields. And as you can see, the format here is that they are splitted with slashes. Let's say that you don't want this format, you want something else. So now how we can change the date format in Tableau? In order to do that, we have to go to the worksheet page. So let's go to the worksheet page over here. And now you have to decide something. Do I want to change the date format for the whole workbook, for the all visualizations? So that means you are changing the default format of the date, or you want to change the format only for this view, only for one visualization. So let me show you how you can do both. So now let's put something at our view. I'm going to take the order ID, drag and drop it over here, and let's work with the order date. So I'm going to drag and drop this on the text. Tableau going to show it as a year, so I want the exact date in order to see the format. So as you can see, our date has the following format. And now I want to change the default date format for the whole workbook. So in order to do that, we're going to go to the left side to the order date, right click, then we go to the default properties, and here you can find the date format. So if you click on that, automatic, it is what Tableau did figure out at the start. And then we have some predefined format from Tableau. What is interesting is at the end we have custom. So our new format for the date gonna split with the dots, and the year gonna have only 2 digits. So the code format gonna be like this: DD for day, then dots, MM for month, and for the year we're gonna have only 2 digits. That's gonna be YY twice. Let's hit OK. And as you can see, Tableau did change the date format in Tableau. So now let's go and duplicate this worksheet over here by right clicking on it and then duplicate. As you can see in the next worksheet as well, we have exactly the same format that we defined. So this means that the format that we defined is a default now for the whole workbook. But now let's say that I want to change it only locally at one visualization, and I don't want to change the default format for the date. So let's duplicate that as well, once again. And now instead of going to the left side, we're gonna stay at the view, and we're gonna go to our fields, right click on it, and then we go to this one here, format. Once you do this, on the left side, the data pane gonna switch to the formats pane. And over here on the left side, you can see dates. So if you click on that, we're gonna get exactly the same stuff over here. Those are the predefined from Tableau. We have the automatic at the top, and at the bottom, we have the custom. So now let's choose one of those predefined. I'm gonna take the week and the year. So let's click on that. So as you can see, Tableau did change the date format in this view. And now interesting to check the other sheets, whether the date format did change. So let's go back to the previous sheets. And as you can see, they stayed at the default format of the date. So with this, you learned how to customize the format of the date for a specific view or for the whole workbook. But now I want to change the date format as before. So in order to do that, I'm gonna go over here, close this format, then go to the order date again, right click, default properties, date format, and then we just click on the automatic and hit OK. So as you can see, we have again the same old date format. So that's it. This is how we can work with the data type date. Alright, now we're going to talk about the last data type in the basic category, the Boolean data type. The Boolean data type represents the fields that has only 2 values, true or false. It's like the language of computer, we have only 1 and 0. And this data type is often used in the output of a condition or logic. So for example, if I ask you, do you like this video so far? So the answer is going to be yes or no. If you like this video, please give it a like. So the answer for this question can has the data type Boolean, either yes or no, true or false, and no any other values. And don't forget to subscribe. So the Boolean data types has many use cases. For example, control the workflow of something. If the output is true, then do something. If false, then do something else. Alright, so now let's check whether we can find any Boolean data type. In our orders, we can check over here. We don't have any Boolean data type. In the customers as well, nothing. And in the products, well, we don't have any field with the Boolean data type. Well, usually data type Boolean gonna be added once we use conditions in Tableau and once we create new calculated fields. And now to create the calculated field, we're gonna go to the worksheet page. So we're gonna go sheet number 1. And now make sure to select the small data source. Then we go to this small icon over here, and now we select create calculated field. So let's click on that. We will get a new window to write our expression or our condition. I'm gonna give it the name of logic. 400. And now what we're gonna check, or what is our condition? If the sales is smaller than 400, then it should be true, otherwise it's gonna be false. The logic is very simple, so here we're gonna find the sales smaller than 400. And that's it. If the sales is smaller than 400, it's gonna be true, otherwise it's gonna be false. Let's click OK. And once you do that, you can find on the left side, we have a new field called logic 400, and it has the data type boolean. The output has only two values, true and false. So let's validate that. I'm just gonna drag and drop this on the view over here. And as you can see, we have only false and true. And let's check whether the logic is working. So we're gonna take the order ID and just put it before it. And now we need the sales. So we're gonna take the sales, drag and drop it here on the APC. And here you can see, for example, the first order, it is smaller than 400. That means the logic is true, which is correct. And then the next one, it is above 400, it's false, and so on. So we can see if the field has only two values, true and false, then the data type gonna be boolean, and we usually use it as an output of a condition. And the boolean data type has a lot of use cases. For example, if you want to filter our data, anything above 400, we don't want to see it in our visualizations. So what we can do, we can use the logic in the filter, just drag and drop that on the filters. And we're gonna select only the true, so I'm gonna unmark the false and then hit OK. And as you can see, the result gonna show only the orders with the sales less than 400. And with that, we just filtered our data very easily. Alright, so with that we have covered the basic 6 data types in Tableau. So now let's do a quick recap. We have the number whole is for fields that stores only numbers without characters, and those numbers are without fractions or decimal dots. Next, the number decimal is as well for fields that have only numbers without characters, but those numbers could have fractions or decimal dots. String is a sequence of any characters. It could be numbers, letters, special characters, or spaces. And then we have date. Date is for fields that stores informations about the calendar dates. Next, we have the date and time is as well for fields that stores informations about the calendar and as well about the time, and it has as well a specific format. And the last type, we have the boolean. It can store only two values, false or true, and we usually use it for conditions. Okay guys, so the first role that we're going to talk about is the geographic role. If you have in your data field that contains location informations or geographical areas, then you can assign it to a geographical role in Tableau based on the type of the location, such as city, country, postal code, and so on. Assigning this extra role gonna help Tableau to plot your data correctly if you are using map visualizations. In Tableau, there are over 12 geographic roles, but I think the most important ones are country, city, and zip code. Now let's check our data, but first, some coffee. Let's go. Alright, back to our data source. Let's go to the customers table. There we have some informations about the location of the customers. And here we have 3 fields. We have country, city, and postal code. And now in order to check the geographic role, just click on the icon over here on the data type. And again here, it's very important to understand, each field must have a basic data type. So for example, the postal code is a number whole, and then we assign an extra role for it. So having the geographic role will not remove the number data type. So now let's check the geographic role over here. And you can see that Tableau didn't assign it to anything, so it stays here none. And this is a zip code or postcode, so we're gonna correct that. So we're gonna just click on this over here to assign a geographic role, and you can see the icon did change. So with that, we have the data type number, and we assigned a geographic role for it. Let's check the others. So this should be a city. So let's click over here. The basic data type is a string because we have characters. And let's check the geographic role. Tableau did it correctly. We have it as a city. So that is correct. Let's go to the country over here. We have it as a string. And then the geographic role is country. So with that, we have all location informations assigned correctly to the geographic role, and we can start building a map visualizations in Tableau. Let me show you an example. Let's go to the sheet number 1 over here. And what we can do, we can go to the customers over here, and let's take the location informations. So let's take the country, the city, and let's have one metric. So I'm gonna take the sales, drag and drop it over here on the APC. So as you can see, it's only a table. We want to switch it to a map. In order to do that, go to the show me over here and then click on the map. So you can see Tableau did correctly plot our data. Let me just close it and assigned for each country the metrics. And this is done because we assigned our data to a geographic role. Alright, so now let's talk about the other one. We have the image role. This is brand new. Tableau just introduced that in 2022. So in principle, if your field stores URLs pointing to images, then you can assign this field to image role with the URL to show the images in the visualizations. And Tableau have here some requirements. So the first one, Tableau supports only those 3 image extensions. And the URL should begin with the HTTP or HTTPS. And the third requirement, the maximum number of images in each field is 500. And then we have the image size. It should be less than 128 kilobytes. But though things might change in the time since it's a completely new feature in Tableau. And I think the most use case for this is to show the product images in your visualizations. Alright, so now let's see an example in Tableau about the image role. In our datasets, I have prepared some URLs inside the table products, but only in the small datasets. So let's check that. If you go to the products over here, we have a field called product images. And here we have URLs pointing to images in my website. So now let's check the data type. Over here, it is a data type string. This is the basic one because a URL is a sequence of characters. And now we can add on top of this basic data type an image role. And it's really easy. We just go over here to the image role and we click on the URL. So let's do that. And with that, we have a new icon indicates that this field has the role of image. So let's check the data. We're going to go to the sheet number 1. Then we go to the products, make sure we are selecting the small data source. Then we go to the products image, just drag and drop over here. And as you can see now, we have some images about the products, but 2 of them are broken. And I think it's still bugging at the desktop version of Tableau Public, because if we publish now to Tableau Public, in the web, we're gonna have all the icons correctly. So now we can go and grab another field. Let's take the sales, drag and drop it over here. And with that, we have a nice images to the matrix. Let's go and publish that in Tableau Public. I'm gonna call it view with image. Let's save. And as you can see now in Tableau Public, we have all icons, nothing is broken. So I think if you are building dashboards about the products, it's really nice to show the image of the product instead of the names. It's just more catchy to have images inside the visualizations. Dimensions and measures in Tableau. So once we connect our data to Tableau, Tableau can analyze our data in order to assign each of our fields to either a dimension or measure. This kind of metadata gonna help Tableau to plot our visualizations. Alright, so now the question is, what is dimensions and measures? Well, Tableau didn't invent the concept of dimensions and measures. It is an old concept of BI, and now we're gonna have a quick origin story. If you learn the concepts of data warehousing and business intelligence, you might already know that the core concept is the multi-dimensional OLAP, online analytical processing. So the concept says if you want to answer the business questions or do data analysis, first we have to build a data model that has the shape of a cube with multi-dimensions. It's something like this cube, and each cube has 2 informations. First, we have the dimensions of the cube, and the second informations, we have those cells. Those cells can store informations like data, numbers, and we call it measures. So each cube has 2 informations, the dimensions, and the cells, the measures. And now let's have an example. We have the cube of sales and it has 3 dimensions. The first dimension is the locations, and inside the locations we have 3 members: USA, France, and Germany. Those 3 values are the member of the dimension location. And we have another dimension called time, and it has 3 members in the dimension: January, February, and March. And the third dimension we have the categories. And now inside the cells of the cube we have the measure sales. So now our cube is ready with the dimensions and measure, and we can start answering the business questions. For example, find the total sales in USA. So what's gonna happen? We can select the dimension location and filter the dimension to have only the member USA. This operation in the cube, we call it slicing the cube. And then we're gonna aggregate the measure and we will get the total sales of 120. And if we have cube, we can do multiple operations like slicing, dicing, roll up, drill down, and pivot. So if you have such a cube, we can do data analysis and find fast answers to the business questions. So now to summarize, dimensions contain qualitative values. They usually describe something like the product name, the product category, customer location, and we use dimensions to categorize, filter, and show the level of details. And in the other hand, we have the measures. They contain numeric, quantitative values that can be measured like the name says. And the measures, unlike the dimensions, they can be aggregated. Alright, so this might be still confusing, and if you say, you know what, if I look to my data, how do I decide whether it's a dimension or a measure? So here is my decision making process. First, I check the data type of the field, whether it is a number. If the answer is no, then this field is a dimension. But if the answer is yes, then we can ask the next question. Does it make sense to aggregate the values of the field? Like doing the sum calculation on the values or finding the average value. If the answer is yes, then it is a measure, but if the answer is no, then it is a dimension. So what this means, all non-numeric fields are dimensions, but not all numeric fields are measures. That really depends on the questions, whether it makes sense to aggregate the values. If yes, then it is a measure. If no, then it's a dimension. Okay, so now let's practice in order to understand the concept of dimensions and measures and how they work. We will check our datasets and we're gonna assign each field to either dimension or measure. We're gonna do the table customers together, and then you can go and pause the video in order to do the products and the orders. And then at the end, we're gonna check the result together. So let's go. We're gonna start with the first field, the customer ID. The customer ID is a number, so we cannot say it is automatically a dimension. We're gonna jump to the next question. Now, does it make sense to aggregate it? Well, we have here to understand that the customer ID is a unique identifier for the customers. For example, Maria has the customer ID number 1, Martin has 4, and now if we sum all those values, we're gonna get the value of 15, or if we do the average, we're gonna get the value of 3. Those values don't make any sense because we use the customer ID only to identify the customers, and I don't think that we will be in a situation where we have to find the average of the unique identifiers. So since it makes no sense, this field is a dimension, and with that we're gonna assign the customer ID to a dimension. Now let's go to the next one. It is much easier because we have here the first name and it is not numeric, so it is automatically a dimension. The same goes for the last name. It is as well a string. It is not a number. All right, so now let's move to the next one. We have the postcode or the zip code. It is a number, so we can ask the question, does it make sense to do aggregation here? Well, I don't think there will be a situation where we have to find the sum of the postcode or to find the average of it. So that means it is here again, it's a number, but it is a dimension. So let's assign the value for that. And then the next one, it is easy. So we have the city and the country. Both of those values are string, so it is automatically a dimension. So let's assign it again. Okay, so let's move to the last field. We have the score. Here it's again a number, so we're gonna ask the question, does it make sense here to do aggregations? Well, the answer is yes. It really makes sense to find the average of the score. That's why we're gonna map it to a measure. So on the table customers, we have 6 dimensions and only 1 measure. And now you can go and pause the video in order to practice with the table orders and as well with the products. Alright, so now let's check the results. As you can see in the table orders, we have a lot of measures because it is a fact table, and fact tables in the star schema is the central place for the measures. So this is very normal. So let's check the fields. We have the order ID, customer ID, product ID. It is like the customer ID. Those are identifiers and it doesn't make sense to aggregate it. So that's why we have it as dimensions. The order date and shipping date, those informations are not numeric and that means it is dimension. And then we have all those informations, the sales, quantity, discount, profit, unit prices, all those fields are numbers, and here it makes sense to do aggregations like the sum or the average. So we're gonna use the orders, the fact table, if we need any measure. Let's go to the next one, to the products, and here this one is easy. The product ID is like again the identifier. It doesn't make sense to do any aggregations. We can have it as dimensions. Product name and category, both of those informations are string, they are non-numeric, and that's why they are dimensions. So I hope with this you have understood how I usually do it. By just looking at the data, we could decide whether it's a dimension or measure. Alright, so now back to Tableau, and the first question is, where do I find in Tableau whether my fields are measures or dimensions? Well, there is no icons for dimensions and measures, and as well we cannot check that at the data source page. In order to check the dimensions and measures, we have to go to the worksheet page. So let's go to sheet number 1. And then we're gonna go to the data pane on the left side over here. Let's open any table, for example, the orders. And now if you look closely to the table orders, you will find like fine gray horizontal line, which splits the fields of the orders into 2 groups. The fields above the line, they are the dimensions, and the fields below the line, they are the measures. So for example, we have the customer ID, the order dates, order ID, product ID, and so on. Those fields are dimensions in Tableau. And the fields below the line, the discounts, the quantity, sales, and so on, those fields are measures. And you can find this splitter, this horizontal line in each table. So if you go to the customers over here, you will see again the same line that splits dimensions from measures. And the same if you go to the products, scroll down, we have again the same line. And one more thing that you might already notice, let me just close those tables, that outside the table there is as well a horizontal line. Sometimes in Tableau we create fields that doesn't belong to any tables, and Tableau gonna put it just outside of the tables. It's like global fields, and for that we need as well a splitter to split the fields to dimensions and measures. Okay, so now let's go back to the orders, and now you might say, you know what, we don't need this horizontal line to identify whether the field is dimension or measure. And now if the field has the color of blue, then it's dimension, and if the field has the color of green, then it is measure. Well, this is exactly where most of Tableau developers get confused and things get mixed up between dimensions measures and discrete continuous. And to be honest, I was thinking the same at the start until I found out that the color of the fields indicates whether the field is discrete or continuous. We're gonna talk about this concept in the next tutorial, don't worry about that. So the color does not indicate whether the field is dimension or measure, but the position of the fields, whether it's above the line or below the line. And let me show you quickly something. Let's take any field over here, the product ID. Let's just drag it a little bit. And now Tableau gonna mark the horizontal line with orange and gonna show you, okay, anything above is dimension and anything below is measures. So Tableau shows that as well. Alright, so now to the next question, how do I change a field from dimension to measure and vice versa? And here you have two options. Either you're gonna do it globally for the whole workbook for all the views, or you might do the change locally in one individual view. So let's see how we can do that. Let's start with the first one where we're gonna do the change for the whole workbook for all views. So globally, we're gonna go, for example, let's take the order ID over here. Just right click on it, and then we go over here, convert to measure. So let's click on that. And as you can see, the field order ID just jumped from above the line to below the line as a measure. And now if you want to change it back to dimension, just right click on it and then convert to dimension. So that's it, it's really easy. And now let's see how we can do the change locally at one view without affecting the whole workbook. So let's take again the order ID, drag and drop it over here. And here we're gonna right click on it on the view. And then we're going to go to the measures. We're going to convert it to a measure. Currently it is a dimension. So let's go to the measures and we have to select one of those calculations. So let's take, for example, the sum. And now as you can see, the order ID only for this view is a measure, but the order ID on the left side for the whole workbook, it stays as dimension. And that's it. This is really easy how you can convert between measures and dimensions. Alright, so now let's have an examples in Tableau in order to understand the main purpose of measures and dimensions. So let's go to the orders on the left side over here in the small data source, and let's take one measure, the sales. We're just gonna drag and drop it on the text over here. And as you can see, Tableau gonna start immediately doing aggregations on the measures. So now if you check the data, we have only one number. This is the total sales that we have in our dataset. And now we are at the top level of details where everything is aggregated in only one number. And now we have to add more informations in order to understand this number. And in order to do that, we're gonna use dimensions. So for example, let's go to the products over here and let's take the category. So I'm just gonna drag and drop the category over here. And as you can see now, the dimension is splitting our measure into two rows. So that means we have now one level lower of details than the top aggregation. And now let's take another dimension. We're gonna take the product name. So let's just drag and drop it over here near the category. And as you can see, using this dimension can give us different level of details about the sales than the first dimension, the category. So what happened? We just moved with the details one more level beneath that. And now let's take third dimension. We're gonna take now the order ID from the orders. So just drag and drop it near the product name. And now as you can see, this dimension gonna bring us to the lowest level of details where the aggregation of the measure is exactly the same original value. And as you can see, the dimensions define the level of details in our views, and each dimension gonna take us to different levels of details. And always if you want to go to the top level of details, you have to remove all dimensions and only have the measure. So as you can see, as we are removing those dimensions, we are going to the top level of details. Another nice way to show that, if we go to the tree map visualization, so let me just go back over here to have one dimension. Let's go to show me and then click on the tree. So now you can see our data is split to only two details. So now as we add dimensions, let's take again the product name over here, drag and drop it on the label. You can see the view split to more details. And if we go to the lowest level, if we take the order ID again over here to the label, we can see the view is split furthermore. And now I'm gonna tell you a small secret. If you follow it, you can generate hundreds of reports, even if you have small datasets. If you combine any measure with any dimension, you will be creating a new view or new reports with a title following this pattern: measure by dimension. For example, sales by product, profit by category, quantity by country. So if you follow this pattern, you can generate endless amounts of reports and views in Tableau. Alright, so now if you count the dimensions and measures in our small datasets, we have around 16 dimensions and 10 measures. So that means if you follow this rule, you can generate around 160 views and reports. So even we have small datasets, we can generate huge amounts of views and reports. So as you can see on the visualizations, if we combine both of them, we're gonna have sales by order date, sales by shipping date, sales by country, and so on. Alright, so now let me just show you how we build usually reports in Tableau using dimensions and measures. We're gonna work now with only one measure, the sales, and we're gonna make dashboards about it. So let's stay at the small data source, and we're gonna take the sales from the orders. Let's just drag and drop it somewhere at the rows. And now the dimension gonna be the product name. So let's take the product name from the products. Let's drag and drop it over here. So that's it. Now we have to call it sales by product. So let's just rename the sheet over here. Right click on it and rename sales by product. All right, so now we're going to create another one using the same measure, but different dimension. So what we're going to do, we're going to go and duplicate it. Right click on it and duplicate. We're going to have now the sales by category. I'm just going to rename it again and let's call it sales by category. And now we're going to remove the product name from here. So just drag and drop it somewhere at the white space. And then we go again to the products, drag and drop the category on the columns. And now we're going to use different visualizations. So I'm going to go to the show me over here and let's use the pie chart. So click on that. All right, so now we have like a pie chart, but I would like to show the values. So go to the label over here, click on it and click on this mark, show marked labels in order to show some values. So that's it. This is our second one. All right, so now we're going to create the third one with another dimension. We're going to take the order dates, but we're going to show only the months. So we're going to go over here and duplicate it again. Let's just rename it. So I'm going to call it sales by month. So we will go now and remove the category, just drop it here. And then let's take the order date, drag and drop it on the columns. We're going to switch the visualizations to par. So I'm going to click on this over here on the pars. So as you can see here, Tableau going to show the years of the order date. We want to have it as a month. So we have to switch that, just right click on the dimension and then over here, just select the month. So let's do that. Let me just close the show me over here and then let's add some labels. All right, so that was it for this view. Let's make the last one. We're going to make sales by country. So let's duplicate this again and we're going to call it sales by country. And then we're going to remove the dimension order dates. And then we're going to take the dimension country. So just drag and drop it on the rows. So now since we have the country, we can change it to a map. So let's do that. We go to the show me over here and then select the map. Click on that. All right, so now we have a map showing the sales by country. All right, so now we have those 4 reports or sheets. We can build now a dashboard. In order to create a new dashboard, we're going to go to this icon over here. Click on it. And before we start, I'm just going to give it a name. So let's call it sales dashboard. All right, okay. And now we're going to go and drag and drop all the sheets. So we're going to start first with the country. So let's just drop it here in the middle. And then we're going to take the category just beneath it. Then the product beside it. Let's resize a little bit to the left. And then we're going to take the last one, the months, and put it over here. And as you can see, with just 4 dimensions and 1 measure, we were able to make dashboards about the sales. And just following this small rule, sales by country, sales by category, sales by product, and sales by month. So always measure by dimension. And now it's really easy to train. Just go and pick another measure with different dimensions and build different dashboards.
Alright, so now let's have a quick summary where we're gonna compare both dimensions and measures side by side in order to understand the differences between them. Let's start with the definition. Dimensions are fields that contains descriptive values and measures are fields that contains quantitative numeric values. For example, we have dimensions like product category, country, and customer ID. And in the other hand, we have measures like sales, profit, and quantity. The next point is about aggregating. Dimensions cannot be aggregated as each member of the dimension is unique. Measures, however, can be aggregated using functions like sum, average, min, max, and so on. For example, you can calculate the total sales for specific product category. Moving on to the data types, all different data types can be used as dimensions like string, date, boolean, and even numbers like we have learned the customer ID. But only the fields with the data type number can be used as a measure. The next point is about the role of analyses. Dimensions are typically used for grouping, filtering, and organizing your data, and measures, on the other hand, are used for calculations and numeric analysis. And the final point is about the granularity. Dimensions define the level of details of the data, and the granularity of measures, on the other hand, determines the quantity being measured. So these are the main differences between dimensions and measures.
Alright guys, so now we're gonna talk about discrete and continuous. Here again, once we connect our data to Tableau, Tableau gonna analyze our data in order to make assumptions where it's gonna map each field to either discrete or continuous. Discrete and continuous are metadata informations that's gonna impact on what type of visualizations that you can create as well as how they will look like. So now in order to understand the concept behind them, we're gonna compare both discrete and continuous. And first we're gonna start with the definition. So this concept comes from math and they say discrete values are always separated, disconnected, distinct values. And continuous values are exactly the opposite. It's like connected value, a serious or unbroken chain of data without any interruptions. So let's have an example. Think of discrete as you are counting from 0 to 10. So you start with 0, 1, 2, 3 and so on. So that means between 0 and 10 we have exactly 11 distinct values. But with the continuous values we have like real numbers, which means between 0 and 10 we have infinite number of real numbers. So for example we have 1.2, 1.3, 1.4 and so on. So with discrete we have distinct values, and with continuous we have a range of infinite values between start and end. Once I read about the discrete and continuous, and the following analogy stick in my head. Think about the discrete values as Lego pieces. So you can take them apart and you can work with each piece differently and independently. So you can move them around and analyze them in different orders. And now think of continuous as a roll of yarn. And now when you unroll the yarn, you will not get different pieces, you will just see more of the yarn. So you will just get a longer piece of the same string. Alright, so discrete values are separated, distinct values, and continuous values are unbroken chain of data without any interruptions. Alright, so now let's move to the next point. We have the colors. In Tableau, the discrete fields are the blue pills, and the continuous fields are the green pills. So let's see in Tableau what this means. Alright, so now as usual the first question is, how do I know whether my fields are discrete or continuous? Well, it's like the dimensions and measures. We cannot check that at the data source page. We have to switch to the worksheet page. So let's do that. We're gonna go over here, and now it's really easy. So now as you hover your mouse on those fields, you will see we have only two colors, the blue and the green. And you can see those colors as well on the data type icons. So we have icons with green and icons with blue. The fields with the blue color, like for example the customer ID, first name, order date and so on, those fields are discrete fields. And the fields with the green color, like discount, sales, unit price, score and so on, those fields are the continuous fields. And here exactly comes the confusion where a lot of Tableau developers think that the blue indicates for dimensions and the green indicates for measures. Well, that's wrong. Those colors to indicate whether it's discrete and continuous. So now you know that.
So let's start with the first one, where we're going to change the role of field globally for the whole workbook. So in order to do that, we're going to go to the data pane on the left side. And as you can see here, for example, the sales in the orders is green pill. That means it's continuous field. And as well, it is a measure. So let's say that we want now to switch it to a discrete field. So in order to do that, right click on the field, and here we have convert to discrete. It's really easy, so let's click on that. And now if you check again the sales, we have it now as a blue pill. So that means now it is a discrete field. So if you check the others, all of them are continuous measures, but only the sales is a discrete measure. And this change is done globally. So if you go to another sheet, the sales gonna still as a discrete field. So now if you want to switch between discrete to continuous, all what you're gonna do is right click on it, and here we have again the same option. We're gonna convert it to continuous. So once we click that, it's gonna go back to the green pill. So that's it. It's really easy. Now we're gonna learn how to switch between discrete and continuous locally for only one view. Alright, so let's build a view. We're gonna drag and drop the sales on the columns, and let's take a dimension, for example the category, drag and drop it on the rows. And now we want to switch the sales from continuous to discrete only for this view. So what we're gonna do, we're gonna go to the sales over here, right click on it, and as you can see the current role is continuous as Tableau mark it for us here, or you can see it from the green pill. All what you have to do is to select discrete. So let's go and do that. And now the field sales is discrete for this view. As you can see, it's blue pill. But if you go to the data pane on the left side, the sales stays as continuous with the color of green. So that's how you can do it locally for only one view. So for example, if you go back to another worksheet and take the sales gonna be a continuous measure. So that's it. This is how you can switch between discrete and continuous fields locally for only one view. Alright, so now let's move to the next point. We have filters. In Tableau, the discrete field gonna create a filter with distinct values, but the continuous field gonna create a filter with range values. Alright, so now let's have an example in order to understand what I mean with those filters. And now we're gonna work with a big data source because we need more data in order to understand this. Alright, so now let's switch to the big data source. Just click on it. And then let's take the sales, drag and drop it over here. And then we're gonna take from the products the subcategory. So drag and drop it on the rows. So now we have the sales by the subcategory. And now if we want to go and filter those values, we can go and put the subcategory in the filters. And don't forget that the subcategory is a discrete field. So let's just drag and drop it on the filters and see what's gonna happen. And now in the new window, as you can see over here, Tableau listed all distinct values inside the subcategory. And now here with those discrete values, we can make decisions individually. So we can include some stuff and remove others. So let's just do that. I'm just doing this randomly and click OK. And that's it. So this is how the filter in Tableau gonna react if we have a discrete field inside it. So we have a list of all distinct values, and we can show this filter on the right side if you just right click on the subcategory over here and then select show filter. So now we have it on the right side, and we can now include or exclude values. And now let's see what's gonna happen if we put on the filters a continuous field. So let's take the sales again, since it's continuous field, but instead of taking it from the left side here from the data pane, you can take it from the shelves by holding Alt and then drag and drop on the filters. So since it's continuous field and a measure, Tableau gonna ask us first, do we want to do the filter on all values or after we do the calculations? So let's go with the sum over here since we have it as a sum. So I'm just gonna click on the sum and go next. And this is exactly what's gonna happen if you have continuous field as a filter. You will get a range. It has a start and end. So you don't have like a distinct values of all the sales. You will get a range of values and you have to define the start and the end. And here we have different options about the range, but we're gonna stay with the first one. So let's hit OK. And now I want to show the filter on the right side. So let's go over here, right click on show filter. And now on the right side, you can see exactly the difference between discrete and continuous fields in filters. So let me just extend it over here. You see the sales is continuous and we have a range. So we can filter like this by changing the start and the end of the range. But with the discrete filter, we have all members of the field and we can decide on each value individually. So we can just select and deselect those values. Alright, so now let's move to the next point. We're gonna talk about the changes in the view. Discrete fields create the headers of the visualizations, where the continuous fields create the axis of visualizations. Okay, so now let's see what this means in our view. As you can see, the subcategory is a discrete field and the sales is a continuous field. And in this view over here, we have three things. We have the marks, those bars, and on the left side, we have the subcategory and we call those informations as headers. And the third information, we have the axis of the view. So what is the difference between headers and axis? The discrete fields like subcategory always create the header of the view. And in the header over here, you have like a list of all distinct values inside our dataset, exactly as it is. But the continuous field like the sales create the axis of the visualization. And it's like the values inside the filter, it's a range that has a start and end. And unlike the headers, you cannot see in the axis all the possible values individually. So you have a range with start and ends, and in between we have pins. So discrete fields create the headers and continuous fields create the axis. Alright, so the next point we're gonna talk about sorting data. In discrete fields, we have many options in order to sort the data, but with the continuous fields in Tableau, it is very limited. So let's see an example. So we're gonna stay with the same example and we're gonna start with the discrete field subcategory. So in order to sort the data in the discrete field, just right click on the subcategory over here on the shelf, or you can go to the header. It's exactly the same, so right click on the subcategory and then we can select over here the sort. So select that, and now we have extra window to set up the sort. So as you can see here, we have many different options like alphabetic, field, manual, and so on. So let's go with the manual over here. And here again, since subcategory is discrete fields, we're gonna get a list of all distinct values, and then we can change the order. For example, by just clicking on the applications, we just can bring it down, and we can take the storage and bring it up, blenders down, and so on. So we can do it manually without any rule. So as you can see, as I'm changing the values, their order in the visualization is as well changing. So if you want to sort the data, we're gonna use the discrete fields in order to do that, since we have many options. And now let's check the continuous fields. So I'm gonna close this. So now if you go to the continuous fields on the sales, right click on it, we don't have here an option to sort the data like in the discrete fields. But instead we have only one option. If you hover on the sales, we have this very small icon and we can use it in order to sort the data ascending or descending.
So just click on that. And as you can see now, the data is sorted by descending values. And if you click on that again, you will get the data as ascending. So sorting the data using continuous field is very limited, but instead of that, we can use the discrete fields in order to sort the data since we have many options. Okay, so now let's move to the next one, and this is really important to understand what is really the purpose of having continuous and discrete in Tableau. The main use case of using the discrete values is to do a deep dives analysis in specific scenario. And in the other hand, we're going to use the continuous values to see the big picture and do trend analysis. Let's have an example. Now we're going to create a new view using the big data source since we have more data. And we're going to go to the table orders. Let's take the order date. Just drag and drop it on the columns, and then we're going to take one measure, let's say the quantity, drag and drop it on the rows. And now as you can see, the order date is a discrete field and we have 5 years of data. But now what we're going to do, we're going to go to the order date, right click on it, and we want to see more details. So just go to the exact date over here. And now as you can see, Tableau did convert it automatically from discrete to continuous value, and we have it as a green pill. And that's because we have a lot of order dates and Tableau tried to bring it all in one picture. And you can see now the order date created an axis with a range of dates. So having continuous fields, you have all the data in one big picture, and that's going to help you to find any trend in your data. So now let's go and convert the order date to a discrete field. So in order to do that, we're going to go to the order date, right click on it and click on discrete. As you can see now, we just broke the chain and we broke the visualizations into individual dates. And now because of that, we have the header and we have all the distinct values inside our data. So we have all the days, all the months of the 5 years in one visual. So with that, having the order day as a discrete, we cannot really do any trend analysis over here because it's really huge visualization. So after we converted the order date from continuous to discrete, we lost the big picture and now it's really hard to do any trend analysis. But now instead of doing trend analysis, we can do now a deep dive details analysis for each individual date in order to analyze a specific problem or scenario, or to answer the question, why do we have in the first place a trend? So you can check the value of each date individually. And we usually use the bar visualizations for the discrete and the line visualizations for the continuous. So let's change that. I will go over here on the marks, and instead of automatic, I will move it to bar. So we have it now here as a bar, and I'm going to just duplicate this sheet and bring the order date as a continuous. And then change the visualizations to automatic. And now I just moved both of the views into one dashboard in order to see the differences between continuous and discrete. So as you can see with the continuous, if you want to make like trend analysis, seeing the big picture, or you're gonna make like a report for the management without showing a lot of details, then go and use the continuous field. And now if you look at the visualizations with the discrete fields, you can use that if the task or the requirement is to do deep dive analysis in the data and evaluate each data individually. So the main purpose of having discrete is to do detailed analysis, where the purpose of continuous values is to do trend analysis.
Alright, so now let's have a summary where we're going to compare both of the discrete and continuous side by side in order to understand the differences between them. Let's start with the definitions. Discrete values are disconnected, separated values, and continuous values are connected, unbroken chain of values. For example, in discrete, between 0 and 10, we have finite number of values. We have exactly 11 values. And in continuous, between 1 and 2, we have infinite number of values. Next one is about the colors. Discrete fields are the blue pills and continuous fields are the green pills. Moving on to filters, discrete fields generate filters with a distinct list of all values available in the dataset. And in the other hand, the continuous fields generate a range filter that has start and end values. And next point is about the views. Discrete fields can generate the header of the view showing all possible values, and the continuous fields generate the axis of the view. Again, it's like a range of values. Then we have sorting. You can use discrete fields to sort your data using different options, but if you sort your data using continuous fields, you're gonna have very limited options. We have only ascending or descending. And finally, we're gonna talk about the purposes. The main purpose of the discrete is to analyze a specific scenario, like you are doing a deep dive analysis in a specific issue. But the main purpose of the continuous is to understand the big picture from the data in order to do, for example, trend analysis over your data. So these are the main differences between discrete and continuous fields.
Alright guys, so now what I'm going to show you is how those different metadata concepts like data types, dimensions and measures, discrete and continuous are related to each other. Alright, so now we have a field in our data, and in Tableau we can assign it to different data types. So it could be string, or boolean with true and false, or a date, and we have as well date and time, or a number, whether it's whole or decimal. And now next Tableau can assign it to another metadata info, either dimension or measure. Any data type that is not a number, it's gonna be dimension. So string, boolean and date, all of them gonna be automatically dimension. You cannot convert it to a measure. And if the data type is number, we could have it as a measure or dimension if it makes sense to do aggregation. And next Tableau can assign this field to the third metadata concept, discrete or continuous. If we have a dimension field with a data type string, it could be only discrete. We cannot convert it to continuous. Like in our dataset, we have the category, the first name, the country. All those fields are string, dimension and discrete. You cannot change it to anything else. The same goes for the data type boolean. It could be only dimension and only discrete. But now if we have a dimension field with a data type date or date time, as you saw in our examples, it could be continuous or discrete. We can have both. And now to the last one, if we have a field with a data type number, it doesn't matter whether it's dimension or measure, we can have this field as continuous and as well as discrete. Alright guys, so with this you have big picture for all those confusing concepts in metadata in Tableau.
Alright everyone, so we have now better understanding about the data types and roles in Tableau and these important concepts. And in the next section we will learn about renaming and aliases in Tableau. How to rename things in Tableau. As we are preparing our data sources, what we usually do is that we're gonna go and rename stuff, like renaming tables, columns, and even give aliases to our data. So first I'm gonna introduce you to the different naming conventions that each developer should know, and after that you're gonna learn the different techniques on how to rename fields and tables in Tableau, and at the end you're gonna learn the different methods on how to add aliases to your data in Tableau. So let's start first by learning the different naming conventions and what are the differences between them. So now let's go. Sometimes in real-life projects, the source of your data might contain technical or unfriendly names. And when you are creating visualizations for the users or your colleagues, you have to make sure that you are using friendly names that are easy to understand and to read. And that's why after you connect your data to Tableau data sources, Tableau will start cleaning up and renaming the fields and the tables to more friendly format. And the format is following a specific naming convention that is decided from the Tableau team, which is really great. So let's understand first what is naming convention. Naming conventions are a set of rules and guidelines that could be used in order to give names for things, like tables, fields, functions, and variables, in consistent and understandable way. Let's say, for example, we have the two words, hello world. In order to create a naming convention, we have to decide on two things. First, the word itself, how we're gonna write it. Here we have three ways. We can use the lowercase, or we can decide to go with the uppercase, or we could use the capital letters. And the second thing to decide is the separator between words. So between hello and word, we have here a white space. Here we have different options. You could use dots, underscore, dash, white space, or even nothing. So now, for example, let's say we're gonna go with the lowercase and the separator underscore. Then we're gonna have the following name, hello underscore world. So with that, we have a naming convention that we're gonna follow through all the projects, and it's really easy to follow. And at the same time, it's very important to decide on the naming convention for your data model, especially at the start of your project. And if you don't do that, I promise you the look and feeling of your visualizations and dashboard gonna look really bad, and the whole project gonna look unprofessional and inconsistent. And one more thing, project team decides on different naming conventions, so there is no really right and wrong here. Alright everyone, so now I'm gonna walk you through the most common naming conventions used in programming languages. The first naming convention is the snake case. Case gonna use the lowercase in all the words and gonna separate them using the underscore. So the name at the end gonna look like snake. Alright, so our example gonna be the customer name, and we're gonna work with this table to fill all the different naming conventions, an example of the output, the rules for the letter case and the separators, and in which applications and programming languages we can find this rule. Where we're gonna start with the snake case. The letter case gonna be here lowercase. and the separator gonna be the underscore. So if we follow those rules with the example, we're gonna have a lowercase customer underscore name, and we can find those formats in Python, PHP, and Ruby. So the snake format is really easy and popular, and you can find it like almost everywhere. And now we're gonna talk about the next naming convention. We have the camel case. And here we have another naming convention that looks like an animal. So in the camel case, only the first word gonna be lowercase, but then all the following words gonna be capitalized. And between the words, there is nothing, no separators, no dots, underscores, dashes, or anything. So at the end, we're gonna have the shape of camel. Alright, so that means we have the second naming convention, we have the camel case. The rule for the letter case is gonna be the following. The first word's gonna be lower, and the rest of the words gonna be capitalized. For the second rule, we have the separation. There is no separation. There is nothing between the words. So here we're gonna write no separation. So now if we apply those two rules in our example, the customer name, we're gonna have the following output. So the first one gonna be everything lowercase. Customer. There is no separation. That means we're gonna start immediately with the second word, but the second word gonna be capitalized. So it's gonna be name, like this. And we can see the camel case is widely used in programming languages like Java, JavaScript, and TypeScript. Okay, so that means we have the third naming convention. We have the Pascal case. It's very similar to the camel case. So the rule says all the words gonna be capitalized. So here we have capitalized, and the separations, there is no separation like the camel case. So there is nothing. So if you follow those two rules on the customer name, we're gonna have the following output. So the first word gonna be customer, capitalized, no separation, then a capitalized name. And we can find this naming convention, the Pascal case, is used in programming languages like Java and C#. I like this naming convention. I used it in many projects. Alright, the next naming convention gonna be the kebab case. And I think by now the one who named those naming conventions should be an Arabic dude. As you can see, we have all the words are lowercase in the skewer and separated with dashes, so the name gonna look like a delicious hot kebab skewer. So now the fourth one, we have the kebab case. And the rule gonna say, okay, the letter case gonna be lowercase, like the snake case, and the separation gonna be here, the dash. So if we follow those two rules on the customer name in our example, we're gonna have the following output. It's really easy, gonna be customer or lower, then a dash, then name. And if you are a web developer or designer, I think you know about this naming convention because it is widely used in HTML and CSS. I think it's like the snake case, it's really easy to follow. And now we have another naming convention. This one is very important, and we call it a title case. It has nothing to do with animals or foods, sadly. So we have here title case. The rule gonna say, okay, the word's gonna be capitalized, and we're gonna separate the words with a white space. So here we're gonna have space. So now if you follow those two rules in our example, we're gonna have capitalized customer, then space, then capitalized name, like this. So why it's important? Because this one is the naming convention that Tableau team did decide to go with. So you can see this naming convention in Tableau. So Tableau currently is enforcing this naming convention in all your data. So once you connect your data to Tableau, Tableau gonna clean up and rename everything following this rule. Well, if you look at it, it's really friendly and easy to read, but sometimes in projects we are forced or we are following some requirements to follow a specific naming convention which doesn't match with the title case. Then the situation is really bad, you have to go and rename everything again. And of course, you don't have to follow one of those naming conventions. You can make your own rules and guidelines. So for example, let's say this is my naming convention and the letter case, let's say it's capitalized, and I would like to separate the words with the underscore. So I'm just mixing stuff around. So if I apply those rules to the customer names, we're gonna have something like this. So capitalized customer, underscore, capitalized name. And with that, we have defined our naming convention. Alright, so now let's check the naming conventions in our datasets and as well in Tableau. So now if you go through the datasets that I've prepared for this course, the small and the big one, you can see that I'm always following the same naming convention. The letter's gonna be capitalized and gonna be separated with an underscore. So for example, on the orders, we have the products underscore ID, or if you go to the customers, you can see the first underscore name and so on. So I'm always following the same naming convention. Alright, so now let's check how Tableau did rename our fields and tables from the datasets. You can check those informations either from the worksheet or in the data source page. But in the data source page, you can find more informations. So now we are at the data source page. Let's go to the metadata grid. And here it's really interesting. We're gonna find two field names. We have here the field name and the remote field name. So what are the differences between them? Well, the information in the remote field names comes from the original datasets. And as you saw, the original dataset is following the naming convention of having underscore between two words, and we have all the words capitalized. So we have, for example, the order underscore ID, customer underscore ID, and so on. So all informations we find under the remote field names comes from the original datasets from the original source system. But now the field name on the left side over here, those informations comes from Tableau after renaming and cleaning up our fields. So if you take a closer look to those names, you can see they are following the title case, where we have capitalized words and separated by a white space. So you can see over here, we have the product space ID, where the original name was product underscore ID. So here Tableau did rename our fields. So here it's really cool. We have in the metadata grid a mapping between the old values, the remote field names, and the new ones after Tableau did rename them. So we have always a data lineage between Tableau and our datasets. As I said, there is no right and wrong here, but it's very important to define those rules at the start of the projects before you start building any visualizations. And I remember one project where we started immediately with building the dashboard and visualizations without deciding first on the naming conventions. So we built around 30 dashboards in Tableau, and after a while, of course, we found out that the developers are using different naming conventions, which is really normal. If you don't define the guidelines and the rules at the start of the projects, then everyone gonna make their own style. So we end up having a lot of dashboards with different rules, and the users were not happy about it at all. So then we decided in the naming conventions, and of course we were too late for that. Then we spent a lot of time renaming the dataset, checking the report, and so on. So if you don't decide at the start of the project, especially if you have like a big project, on the naming convention, then you're gonna have really painful and costly process of renaming everything from the scratch. So make sure at the start to take enough time to talk to your users and the project team to decide on the naming conventions, and very important in the review process of any new dashboards in Tableau, that to check that the naming conventions are followed in each workbook to be consistent in the whole project. Alright, so now let's say that you decided together with your users and the project team on specific naming convention, which is different from the one that Tableau uses. So now the question is how to rename in Tableau. So in Tableau, we can do the following changes on the table. So we can rename the table itself, or we can rename the fields inside the table. And the last one, we even can change the values inside these fields, also known as aliases. We're going to talk about it in the next tutorial. So in this tutorial, we're going to focus on renaming the fields and renaming the tables. So first, let's learn how to rename the fields in Tableau. Alright, so now we're gonna learn how to rename fields in Tableau. Let's have the following task. So the task says, rename our fields in Tableau following the naming convention Pascal case. So that means all the words are capitalized and no separation between words. Alright, so now the first question is, on which page we can rename our fields? We can rename our fields either in the worksheet page or in the data source page. We're gonna get the same effect. But I usually go to the data source page, since there we can find more metadata informations about the fields and tables. And now the second question is, can we rename our fields globally for the whole workbook for all worksheets? And as well, can we do it locally for only one view? Well, you can do both, but renaming locally for only one view is a little bit tricky. So now let's learn how to rename our fields globally for the whole workbook for all views in the worksheet page. Okay, so now let's go to the worksheet page over here. Then we're gonna go to the data pane on the left side. We will rename the shipping dates. And here we have three methods. The first one is the drop down. So what we're gonna do, right click on it and then simply go to the rename. So we're gonna click on that and we're gonna rename it to the Pascal. So I'm just gonna remove the space between them, then enter. And that's it. It's really easy. We just renamed the shipping dates. And the second method is to use a shortcut. So for example, let's go to the order date over here and hit F2. And with that, we can edit the name. So I'm just gonna remove as well the space between order and date, and hit enter. So as you might already noticed, the position of the order date just changed in the data pane, and that's because the fields in the data panes are sorted in alphabetical order. So that was the second method using the F2, using a shortcut. And the third method to rename the fields in the worksheet page is to click and hold. So for example, let's go to the unit price over here, left click and hold, then release. As you can see, we can now edit the name. So this is the third one. I'm just gonna remove the space between them and hit enter. So that's it. Those are the three methods of renaming the fields in the worksheet: drop down, a shortcut using F2, and click and hold. And one more thing about renaming, unlike the aliases, which we're gonna learn later, can rename any type of fields. So whether it's dimension, measure, continuous, discrete, any type, we can rename it. So there is no restriction or whatever for renaming in Tableau. All right, so now let's go to the next one. We're gonna rename the fields in the data source page. So let's go to the data source page over here. And here we have two places where we can rename stuff, either at the metadata grid or at the data grid. And here we have only two methods to rename stuff. So the first one is gonna be the drop down like the worksheet page. So let's go to the name, for example, the order date, right click on it and then rename. So we're gonna remove the space between them and that's it. And the second method to rename fields in the data source page is by double clicking. So for example, let's go over here on the metadata grid to the customer ID and just double click on it. And now we can go and as well, we're gonna remove the space. So that's it. So this is how we can rename in the data source page. We have only two methods, the drop down and the double click. Here we don't have sadly any shortcuts. All right, so now we have the following scenario where we have renamed the fields like several times and we forgot the original names of the fields. So in this case, we can reset everything back to the original names. And we can do that either at the data source page or at the worksheet page. Let's see how we can do it on the data source page. So if you just go to the field, for example, the customer ID, right click on it, then here we have the option reset name. So let's click on that. So as you can see now, we are back to the original name of the field. I found it really strange because I would like as well to have the option of resetting to the Tableau naming convention. So now let's see how we can do that on the worksheet page. I'm gonna switch back and then go to the data pane. Let's pick the order dates. And now we're gonna go and edit the field again. So right click on it and then rename. Then you can see over here a very small icon to reset to the original name. By clicking on it, we reset the field to the original field name. All right, so now let's say that you have a lot of fields and you want to reset all of them. Now, instead of resetting them one by one, we can do multi-selection and then do reset. And we can do that at the data source page. So let's switch there. And here it doesn't matter whether you're gonna work with the metadata grid or at the data grid. So now what we're gonna do, we're gonna go to the order ID, click on it, and then hold Control, select the next one, and then we're going to select the unit price as well. Then right click and reset names. Once you do that, you're going to reset all of them, which is really nice. So we have the unit price resetted, the shipping date, and as well the order date. All right, so now we have the following scenario where you are in the project and you build already a view, but afterward you decided to do renaming. So what can happen to our view if we do renaming? So for example, here in the view, we have the order underscore ID and we want to rename it back to the Tableau name. So we're going to go to the order ID, F2, and then instead of underscore, I'm just going to leave it as a white space. So as you can see in the view, Tableau did change the names automatically to the new name. Well, you might say, okay, and what? This is expected. If I change the name of the data source, it's going to change as well in the visualizations. Well, this is only in Tableau. If you are using any other tools like Power BI and you do renaming at the datasets, the whole visualization going to break. So here, if you have the task of renaming, this is going to happen fast in Tableau, but in Power BI projects, it's going to be really painful. All right, so far we have learned how to rename the fields globally for the whole workbook. Now the question is, how to rename locally for only one view. And here it depends on the field roles, discrete and continuous. So let's start now with the continuous. As we learned before, the continuous can generate the axis of the view. So here in this example, as you can see, the quantity and sales are the green pills. That means they are continuous and they generated the axis of the view. Now to rename the quantity over here and the sales, it's really easy. What we're gonna do, we will go over here on the axis, right click on it, and then go to edit axis. Let's go there. Then here we have a new window, and if you go over here, you can see the axis titles, and the current title is quantity. So let's go to the field over here and change it from quantity to quantities. Then let's close this. And as you can see now, the field name called quantities on the axis. And if we check the data pane over here, the field stays as quantity. So we did this change only locally at this view. And this is really easy for the continuous, but the tricky part is if we have a discrete field. For example, the order ID over here is discrete. So we have the blue pills. So this one gonna be tricky. So now we're gonna change the name from order ID to orders. So what we're gonna do, we're gonna go to the blue pill over here at the rows and double click on it. Double forward dashes, write the word orders, then press Shift Enter. And that's it. Go outside, just click here in the white space. And as you can see now, we have renamed it to orders and as well here in the view, but we didn't change the global name. It stays as order ID here at the data pane. So this is how we rename the discrete fields locally at one view. So it was not really clear. It's like tricky, but let me show you how I usually do it. Let's take another field, the category over here. We're going to change it from category to categories. So what I usually do, I go over here and double click on it and just I copy the name. Then I go to any text editor and paste the name. Then before it, we're gonna have the new line, then double dashes, and we're gonna have the new name categories, and that's it. So then I'm gonna copy it from here and go back to Tableau. Then I go again inside the category over here, double click on it. Then I remove this part and just paste the new stuff, then enter. So that's it. This is how I usually do it for the discrete fields. I go to the text editor and prepare there since it's more clear for me what I'm writing. All right, so now we have learned all different methods of renaming fields in Tableau at the data source page, the worksheets page, globally and locally. Alright, so now we're gonna move to the next point where we're gonna rename the tables in Tableau. And here again, we can do the changes either at the data source page or at the worksheet page using the same methods as renaming fields. And the next point about locally and globally, you can change the names only globally. So anything you do, it's gonna affect all the views, which is not really critical as the field names. So now let's see how we can do it at the worksheets page. So we're gonna stay with a small data source over here and let's minimize everything so we see the table names. So you might already notice that on the names we have .csv, and that's because our datasets comes from CSV files, which is not really useful information to see it at the data source. So we can go and clean up the name and rename it to only, for example, customers. So we can go to the name over here, right click on it and then click rename. So I'm going to rename it to only customers. And the next one, we're going to use the second method using the shortcut F2. So let's hit F2 and remove the SV parts. We have only the orders, and we're going to use the third method for the products. Just click and hold, then remove the CSV parts. And that's it. Those are the three methods for renaming tables at the worksheet page. Now let's do the changes for the big data source at the data source page. So let's switch there. We're going to go to the data source page, and here you have two places to change the table names, either at the data model or at the metadata grid. So we cannot go to the data grid to rename tables. So first, let's switch to the big data source. I'm going to go over here, then big data source. So let's change the orders at the data model. So here we have only one method, right click on it and rename. So we're going to remove the CSV parts, and then we go to the customers over here. Then let's go to the metadata grid. And as you can see, just click over here and you can remove the CSV parts. So that's it. And now for the last one, we have to rename the product. So we can go over here and select the product, and then we're going to rename it in the data source page. So that's it. So this is how you rename the tables at the data source page. We have the data model and the metadata grid. So with that, you have learned all the possible methods on how to rename tables in Tableau. Let's first understand why and when we need aliases in Tableau. Sometimes in Tableau projects, we face the following situations. The first one is when we have a poor data quality in our datasets, wrong data, typo, or inconsistent values. So we have somehow to clean up our data before we start building our visualizations. For examples, we have the following scenario in the table customers. We have bad data quality inside the field country. So here we have a typo. Sometimes it's Germany, sometimes it's Deutschland, sometimes they call it USA and then America. So the data quality is really bad in this table. So here we have to do something about it and clean up the data. And here we have two options. Either we go back to the original data sets and do the changes on the values, and the second option, we can do the changes directly in Tableau using aliases. So how we're gonna clean this up? We're gonna remove the E from here, the typo, and then instead of Deutschland, we're gonna have Germany, and instead of America, we're gonna have USA. And we might have another situation where the data quality is good, but the names are too long. And if you are building views, you will understand that everything is tight and you don't have enough spaces to show the whole values of the dimensions. That's why we end up most of the time changing the values of the dimensions to shorter names, to abbreviations. So for example, instead of having the value Germany, we're gonna have DE, instead of USA, US, and here FR, DE, and US. And here again we have the same situation. Either we're gonna go back to the original dataset and change the values, or we stay at Tableau and do it directly there using aliases. And in real projects, you cannot go each time back to the source system or to the original datasets and change the values there. Either you don't have the time for that or you cannot do that. That's why we end up always changing those values directly in Tableau. So aliases in Tableau are alternate names for the member of a discrete dimension field, so that their labels appears differently in the view. As you might notice, I say it's discrete dimension field, and that's because Tableau does not allow you to create aliases for measures or for continuous dimensions. So in Tableau, you can create aliases only for the fields with the role discrete dimension. And now, as usual, we have the questions on which page we can create aliases. Well, only on the worksheet page we can create the aliases in Tableau, and we cannot create it in the data source page. And the second question, can we create aliases globally for the whole workbook, all the views, and as well locally for only one view? And the answer for that, we can create aliases only globally that gonna affect the whole workbook, all visualizations. So we cannot create aliases locally for only one view. Okay, so we're gonna go to the worksheet page. We cannot do it at the data source page. We're gonna stay at the small data source. Let's take the countries, drag and drop it over here on the rows. And then let's take any measure. Let's take the scores, drag and drop it on the columns. So the task here, instead of having those values, France, Germany, USA, we want to have short names. So here we have two methods to create aliases in Tableau. The first one is to go to the data pane on the left side. So let's go to the field country over here, right click on it. And then here we have the option aliases. So let's go there. And here we're gonna get a new window to edit the aliases. So let's check what we can see over here. So in the middle, we have three columns. We have members, has aliases, and value the aliases. The first one, we're gonna see all the members of the dimension country. Those values comes directly from the datasets. So those are the original values from the source. Then the next one we has aliases. It is like an indicator to show us whether the values in the view gonna come from the original values or from the aliases. And now it's all empty because we didn't add any aliases. And the third field, we have the aliases. Here we can go and edit the aliases of each member individually. And as you can see now, the aliases are exactly identical to the original values. That's why we don't have any aliases. So now let's go and change that. Instead of France, we're gonna have FR, and then instead of Germany, we're gonna have DE. And as you can see, as I'm adding different values in the aliases from the original values, Tableau gonna mark it as a star. So now let's go for the last one, and we're gonna have it as US. And now just check what's gonna happen once I click OK. You see here we have the old values, and if I click OK, switches to the aliases. And that's it. This is how you can add aliases in the data pane. But now let's say that you change your mind later and you don't want to use the aliases, and instead of that you want to go back to the original values. So how we can do that? Maybe you already saw it. So let's go back to the country over here on the data pane, right click, we go again to the aliases, and while editing the aliases, there is here an option called clear aliases. So what you can do, you can go over here and just click on it, and everything gonna reset to the original values. And as you can see, those indicators did vanish. That means there is no aliases. So now if you go and hit OK, the value is gonna go back to the original values from the dataset. And here what I usually do once I need aliases in Tableau, I don't go directly to one field and change the values, but instead of that, I tend always to create a new duplicates of the field and only change the values of the new fields that I have created. So let me show you what I mean. So we go to the country, then right click, and then we go to the option over here, duplicates. So let's do that. And as you can see now, we have another field called country with the copy. And of course, now from the name, I can understand this is copy and the other one is the original. But in Tableau, if you look very closely to the data type icon, you can see that in the duplicates, we have like an equal sign. This sign indicates that this field is not original one, but it is created from another original field. So if you see the sign, that means this is a customized field that we have created. So what I usually do, I go and rename it. So we're gonna call it country short. And now I create the aliases on this new field. So let's go and do that. Right click, aliases, and then instead of France, FR, DE, and US. So with that, I have the two options, the long one, the original one, and as well the short version of the country. And I can decide in each visualizations whether I'm going to use the short version or the long version. Alright, so that's all for the first method, where we created aliases from the left side from the data pane. And now we're going to go to the second method, where you can create aliases directly from the view. So let's see how we can do that. Just move over the value France over here, and right click on it. And then here we have the option edit alias. So let's select that. And now here I have very simple window. I just have to edit the alias of only France. So I'm giving the alias only for one value. Let's do that. So FR and then hit OK. And as you can see in the view now, we just changed the value France to FR quickly from the visualization. And we can do the same for Germany. So right click on the value, then edit aliases. Again, the same window. We're going to say DE. And OK. And as well, the value changed directly in the view. So this is really quick method to edit the aliases directly in the view. And now if we go and check the dimension country in the data pane, so let's check the aliases. As you can see, the member France and Germany has an alias, FR and DE, and we done that directly from the view. So now the question, which method to use? I would say if you want to change multiple values, go to the data pane and do the changes. It's just easier to work with the window and add all those values. But if you want to change a single value from the dimension, then you can do it quickly by going to the view and edit the alias. And that's all for the aliases. This is really great way how to clean up, how to change the values directly in Tableau without having you going back to the original datasets and doing the changes there. Alright, so now we have the following Tableau task for you. The task says, abbreviate the values inside the field category in the table products from the big datasets, showing only the first character from each value. You can pause the video right now to do the task, then resume it once you are done. Alright, so now let's do that quickly. As I showed you before, first we start with duplicating the field. So I'm gonna go and do that. Then I'm gonna rename it to category short. Then I'm gonna present both of the values, so category and category shorts. So far, both of the dimensions has exactly the same values. We didn't change anything. Now we're gonna go to the category short, right click on it, and then we're gonna go to the aliases. The task says the first character, the first letter from each value. So that means the first one gonna be F. The second one, it could be O or OS. So I'm gonna leave it as O. And the third one gonna be T, then click OK. And that's it. Now we have new dimensions that has only the first character of each value. And we have done that using the aliases. This is really easy. Alright guys, so with that we have completed this section, which is a really important step in order to prepare our datasets before we start building our visualizations. In the next section, we will learn how to organize and structure our data in Tableau. How to organize your data in Tableau. In Tableau, we have different techniques and methods on how to group up and organize your data, which is very important for your users to understand your data. So first, you're going to learn how to organize the dimensions in hierarchies. And after that, you're going to learn how to group up the members of dimensions using groups. Moving on, we're going to learn how to cluster your data into different groups using the cluster group. And after that, you're going to learn how to split your data into two subsets using sets. And then we have another method called bins in order to group up the values of the measures in order to build histograms. So let's start with the first method of organizing our data using hierarchies. So now let's go. Alright guys, so the best way to understand the hierarchy is to have an example. If you take a look to our data, for example the customers, you can find some dimensions are related to each other's since they hold similar informations. For example, the dimension country, we have values like Germany, USA and France. And we have another dimension city where you can find the cities inside those countries. So for Germany we have Berlin, Stuttgart. And then we have a third dimension, postal code, where you can find the codes inside those cities. So as you can see, these three dimensions are describing a common information. They give us informations about the user location, and we can relate those dimensions together using the hierarchy. In hierarchies, we have different levels, and we start with the top node and we call it the root node. This node represents the highest level of aggregations in our hierarchy. And now we're gonna go to the next level of the hierarchy where we have the country. And in this level, we're gonna see more details about our data, where we have, for example, the two values USA and Germany. And the links between the nodes, we call it branches. And now we're gonna go to the next level in our hierarchy. We have the level 2, city. So here in the city, we will see more details about our data. So in USA, we have Portland and Seattle. And in Germany, we have Stuttgart and Berlin. And again, we have the link between the parent node and the child node using the branches. And now we're gonna go to the last level in the hierarchy. We have the postal code. And here we're gonna split the structure furthermore with more details. So we have the following postal codes for each cities. And now since the postal code is the last level in our hierarchy, and those values don't have any children, we call those nodes as the leaf nodes. The leaf nodes, or the leaves, they represent the most detailed level of our data in this hierarchy. So now with that, we have the complete structure of our hierarchy, and as you can see, it looks like a tree structure. The top node, we call it the root node. It represents the highest level of the details. Then we have the intermediate levels, and they are connected using branches. And the last level, we call it leaf nodes, where it represents the lowest level of details. So we have the root node, it represents the highest level of the aggregations. Then we have intermediate levels connected with the branches, and then we have the leaves, the leaf nodes. They represent the lowest level of details in our data. So as we learned before, we can do many OLAP operations on the cube. So if we have a hierarchy in our data, we can do two very important operations, the drill down and the drill up. The drill down and drill up, they are OLAP operations that's gonna help us to navigate through the hierarchy in order to gain deeper or higher level understanding of the data. So let's understand first how the drill down works. Let's say that we are working with the measure sales. We start on the top node on the highest level. So at the highest level, we're gonna have the total sales in the whole data sets. For example, it's gonna be 140. So now we are at the highest level at the root node, and if you use drill down, you're gonna jump to the next lower level in the hierarchy. So that means at this level, we're gonna see more details about the sales. So for USA, we have 90, and for Germany, we have 50. And now if you want to see more details about your data, we're gonna apply again drill down in order to jump to the next lower level in the structure. So what's gonna happen? We're gonna go to the level 2, and here the sales gonna split between Portland and Seattle. We have 40 and 50, and for Germany, we're gonna have 20 for Stuttgart and 30 for Berlin. So that means we are seeing more details about our sales. And now if you want to go to the lowest level, to the leaves, we're gonna drill down from the city to postal code. So it's gonna look like this. The Portland gonna split between those two postal codes. So Seattle gonna be the same because we have only one child. The same for Stuttgart, it's gonna stay 20, and Berlin, we have two postal codes, so it's gonna split again. So as you can see, we are using drill down to navigate through the hierarchy by taking us from higher level to lower level of details. It's like we are expanding the tree to see more details to understand our data. Alright, so now we're gonna talk about the second OLAP operation, the drill up. It's exactly the opposite of drill down. Drill up gonna take us from bottom to top, from lower to higher level of details. So how it works, let's say we're gonna start at the leaves, and we're gonna have the sales of those leaves. And now we can use a drill up to move from the postal code to the city. So for example, we're gonna have the total sales in Berlin 30 because it's the sum of 10 plus 20. And then in Stuttgart, gonna stay the same 20, Seattle 50, and Portland as well, gonna sum up the values from the leaves. So we're gonna have the value of 40. So as you can see, as we are moving higher, the value is gonna get more aggregated. Let's say that we want to jump to the country, so we can use again a drill up to move from the city to the countries. So for Germany, we're gonna have the total sales of 50, and for USA, we're gonna have the total sales of 90. And now you can use again drill up to go to the root node where you're gonna have the highest level of aggregations. So we're gonna have the value of 140, the total sales inside our data set. So as you can see, if we have a hierarchy structure, we can use a drill up and drill down to navigate through the hierarchy structure. So hierarchies organize and structure the member of the dimensions into a logical tree structure by grouping similar dimensions together. Hierarchies are really important and give dynamics to your views, where you can have the big picture and understand the data at the highest level, and you can drill down to specific details to gain deeper knowledge about your data. Alright guys, so now we are back to Tableau. Let's understand how we can create hierarchies in Tableau. We can create hierarchies only on the worksheet page. We cannot create it at the data source page. And in the worksheet page, we can create hierarchy on the data pane page. And if you take a look to the customers tables, you can find that we already have a hierarchy. And here we have a small icon that indicates we have a hierarchy. The hierarchy name called country city. And on the left side over here, we have small arrow. If we click on it, the hierarchy gonna expand and we can see the dimensions inside this hierarchy. Speaking about dimensions, hierarchies could be used only for dimensions. You cannot create a hierarchy from measures. And this hierarchy that we have over here, it is created automatically from Tableau, since Tableau analyzed the content of the country and the city and automatically understood that there is a hierarchy between them. But since we want to learn how to create a hierarchy, we're gonna go and remove it and create a new one from the scratch. So now in order to remove a hierarchy, you go to the hierarchy name over here, right click on it, and then here we have the option remove hierarchy. Here you have to understand that the dimensions inside the hierarchies will not be deleted, only the hierarchy itself will be deleted. So you will not lose any fields, only the logical tree, the logical hierarchy will be removed. Alright, so now let's see how we can create hierarchy in Tableau, and we're gonna create the location hierarchy. We're gonna go to the left side to the data pane and we're gonna select one of the dimensions. It doesn't matter which one you're gonna select, but I prefer to start with the highest level of the hierarchy. So here in our example, it's gonna be the country. So select the country, right click on it, and then here we have something called hierarchy, and we're gonna select create hierarchy. So let's go there. We have to give it a name, so we're gonna call it location hierarchy, and then hit OK. As you can see now on the left side, we have the icon of the hierarchy, and inside it we have only one dimension, the country. Now in our hierarchy, we have as well the city and the postal code. So how we can add it to this hierarchy? As we learn, the hierarchy has different levels, and the order of those levels are really important. So we have country, city, and postal code. So now in order to add the city, we're just gonna drag and drop the city beneath the country over here and release it. So with that, we have now the city inside our hierarchy. Let's grab as well the postal code. So we have to drag and drop it beneath the city. Let's release. And with that, we have created the location hierarchy with the 3 dimensions, country, city, and postal code. So here again, if you want to hide the details about this hierarchy, we can collapse it over here. Or if you want to see the details, we can expand the hierarchy. Alright, so this is one way on how to create hierarchy in Tableau by using drop down. The second way on how to create hierarchy, we can quickly drag and drop dimensions together. So for example, if we go to the products table, we have as well a hierarchy here between the category, product name, and subcategory. So our hierarchy starts with the category, then the subcategory, and the last one, the leaves, gonna be the product name. So now let's see how we can create the hierarchy using quickly drag and drop. We're gonna take one of those dimensions. Let's say we're gonna start with the category, drag and drop it inside the subcategory. So I'm now hovering and selecting the subcategory. Let's release. Once we do that, Tableau understands that we want to connect those dimensions. So Tableau gonna create a new hierarchy. We're gonna call it the product hierarchy, and let's hit OK. And now let's see on the left side, we have new hierarchy called product hierarchy with the icon, and we have inside it 2 dimensions, category and subcategory. We are missing the 3rd dimension. Let's take the product name and drop it in the hierarchy. So now we have problem with that. The order of the dimensions inside our hierarchy is wrong, because the dimension category should be the level 1 and the subcategory should be the level 2. So how we can fix that? Just select the category and drag and drop it on top of the subcategory. Let's release that, and that's it. This is how you change the order of the categories, and with that we have the product hierarchy. Alright, so now let's say that we want not to remove the whole hierarchy, we just want to remove one member, one dimension from the hierarchy. So in order to do that, let's say we want to remove the product name, select it, and just drag and drop it somewhere here in the empty space. And with that, the product name is not anymore member of the hierarchy. So this is how we can remove dimensions from hierarchy, but I want to put them back in our hierarchy because we need it later. So I will put the subcategory beneath the category, and we take the product name and put it beneath the subcategory. And that's it. So these are the 2 methods of creating hierarchies in Tableau, either by drop-down menu or by quickly drag and drop the dimensions together in order to create a hierarchy. It's really easy. Alright, so now we have this hierarchy, this structure. How are we going to use it inside our view? It's really easy. We're going to go and select the whole hierarchy, then drag and drop it to the view. So here the hierarchy gonna start from the level 1 for the countries, and we're gonna see the values of the country. And now let's have one of those measures. We're gonna take the sales and drag and drop it on the columns. So now if you look closely to the country, to the blue pill over here, you can see that we have a new sign, the plus sign. This sign indicates that we can drill down in this dimension. So now let's go and click on the plus sign. As you can see now, we are drilling down in our hierarchy to a lower level. So now we are seeing more details about the sales, and we are now at the level of the city to the next level. So now as you can see, we have the dimension city in our rows. We didn't drag and drop it from the data pane and put it at the rows. It expanded from the hierarchy. And again here, the city has the plus sign that indicates we can drill down inside the city. So let's drill down again. So as you can see now, we are at the postal code and we can see more details about the sales. And now if you check the postal code, there is no plus sign like the city and the country because we are at the leaves. We are at the lowest level of details in our data. So with that, we have navigated through our hierarchy from the top node to the leaves. As you can see, it's really easy and very dynamic. So now let's say that we are at the leaves and we want to drill up back to the highest level of the aggregations, back to the top node. It's really easy. If you check again the city and the countries, we don't have anymore the plus sign, we have the minus sign. The minus sign indicates that we can drill up in the hierarchy. So let's see what's going to happen if you click on the minus sign. As you can see, we drill up now from the leaves, from the postal code, back to the city, and the values of those sales are now more aggregated. And now the same thing, if you want to drill up from the city back to the country, we're gonna click on the minus sign. So let's do that. And with that, we are moved to the level 1 to the highest aggregation in our hierarchy. Alright, so far what we have done is we drill up and drill down in our hierarchy using the row shelves. And you know that the rows and the columns, we use it as developers to build our view. So now the question is how our users and the audience gonna drill up and drill down through the hierarchy, because the hierarchy should be as well used quickly from the users to drill down to the details. So now let's see how we can do that. If we go to the view over here and hover on the country, we can see again a plus sign. So let's go and click on that. And as you can see, we drill down in our hierarchy from the country to the city. So now let's go more in details and drill down to the postal code. We can hover on the city, and as you can see, we have again the plus sign. So click on that, and with that we drill down to the postal code. So this is exactly how the user is gonna drill down in the view. So now if we want to drill up back to the higher level, we can do the same. We can see the minus sign over here. Click on it and you go back to the city, and then we go to the country as well. We have the minus, we click on that, and with that we drill up back to the country. So as you can see with those icons, we can navigate through our hierarchy. So now you might say, oh, your users, you know what, this is really small icon and my users don't like it. So is there any other way to drill up and drill down in the view? Well, yes, if you go to any of those values over here and right click on it, you can see in this drop down we have a drill down. So if you click on that, we drill down to the city. The same if you select any value, doesn't matter which one. Let's go over here and then drill down again, and with that we are at the postal code. If you want to drill up, you can do the same, any values, right click on it, and here we have the drill up. So select that, and to drill up back to the country, go to any values in the country, right click on it and drill up. So those are the two ways on how to drill down and drill up in the view. Alright guys, so far we have created our own hierarchies by putting those dimensions together in different levels. But in Tableau we have as well indirect embedded hierarchies in the data type date. In Tableau, any field with the data type date has the following hierarchy. It starts with the highest level with the year, then we have the quarter, then month, and then the lowest level, the leaves, we have the days. So those four levels are the default levels inside each field with the data type date in our dataset. And now we have another data type that holds as well an embedded indirect hierarchy. We have the fields with the date and time. So here we have informations about the time, and we have 7 levels. It starts exactly like the date, so the highest level gonna be the year, then the quarter, month, and then the day. But now we can drill down to more details since we have the time information. So the next level gonna be the hours, then we have minutes and seconds. And the seconds are the lowest level of details, they are our leaves. So here we have 7 levels of the hierarchy. So date and time, they have hierarchy embedded inside it. So now let's uncover those hierarchies in Tableau. Alright, so now we're gonna go to the table orders, and here we have 2 dates, doesn't matter which one, both of them are gonna have exactly the same hierarchy. So let's take the order date, drag and drop it here on the rows. And now as you can see, we have now the plus sign. It indicates there is a hierarchy and it starts at the highest level with the years. So now let's take a measure to see some data. We're going to take the order counts and put it in the columns. And I want to show as well the labels. So let's show some labels. All right, so now let's go and discover the hierarchy inside the date. As you can see on the left side, we don't see any information about the hierarchy. So that means it's really embedded inside this data type. So let's go on the years and click on the plus sign to drill down. As you can see, the next information, we have the quarter informations. So now we see the total number of orders by the quarter. So now we can see more details about the total counts, and then we can drill down to the day. And now we are at the lowest level at the day. We cannot drill down further to, for example, hours, minutes, and seconds, because the order date has the data type date. So as you can see, the dimension order date has 4 levels: years, quarter, month, and day. It's really nice to have it like this in Tableau because it's really standards. I worked with other BI tools, and there we have to build it in our own, which is really time consuming to build all those hierarchies, especially if you have a big data set. So here in Tableau, our life is easier. Tableau did decide to have hierarchy inside each date. Alright guys, so one more thing about the hierarchies, they really organize and structure your views and make it more dynamic for the users. So for example, if you have the requirements to make sales by country, sales by city, sales by postal code, and you don't use hierarchies, you will end up making 3 views, like here on the left side. So it takes a lot of space, and as well, it's not really dynamic. But better than that, we can create hierarchy between those dimensions, and we can put everything in one view, and then you give the options for the end users to drill down and drill up depending on what they need. So here, if they want the sales by country, we have it already at the top node. But if they want the sales by city, all what they have to do is to drill down to the next level, and we have it already sales by city. And if someone's need to go more in detail to go to the postal code, they can drill down as well to the sales by postal code. So as you can see, it gives really your view more dynamic and gonna be more attractive for the end users. So if you compare to the left sides, now we have more dynamic, more interactive for the end users, and as well you are creating less views in your dashboards. So this is really great. So if you want to drill up back to the country, we can just click the minus sign. So hierarchies gives more dynamic, its structure, and organize your data in the views. Alright guys, so now let's summarize. Hierarchies organize and structure the members of the dimensions into logical tree structure. And hierarchies are special feature only for dimensions. You cannot create hierarchies between measures. And we can use drill down and drill up to navigate through our hierarchy to gain deeper or higher level understanding of your data. Overall, hierarchies are really important to organize and structure your data in the views, and it provides for the users a powerful tool to quickly and easily navigate and explore your data, uncover insights, and make better decisions. Alright guys, so far we have learned how to group up the dimensions together in hierarchies, but now we will learn how to group up the values, the members of the dimension, into groups. And in Tableau we have 3 methods in order to do that. So we have the groups, cluster groups, and sets. And now we will start with the first one, how to group up the members of the dimensions using groups. But now as usual, let's understand first the concept behind it, and then we're gonna learn how to build it in Tableau. So let's go. Alright, so now if you take a look to our data, sometimes you're gonna find dimensions that could be used to categorize or to group up the data inside this table. So for example, if you take a look to our products data, you can find that the category can be used to group up the data. So for example, you can see 2 products are assigned to the category monitor and 3 products are assigned to the accessories. So this field could be used to group up the data. And now if you check the customer's data, you can find some dimensions that could be used to group up the data. For example, the country, the city, the postal code, those information can be used to group up the customers. So all those dimensions could be used to group up our data. So those groups or those dimensions comes directly from the datasets, and we didn't create so far anything. So sometimes we might be in a situation where we want to group up the data differently than the original groups in the datasets. So here we have 2 options. Either we go back to the original datasets and do the changes there, I create the group, or we can create the group directly in Tableau without going back to the original datasets. So for example, we want to create a new group in the products, and it's gonna be the product class. So here we have another group, and we're gonna call, let's say for example, the first 3 are the class A, and the last 2 are the class B. So we can create this extra group directly in Tableau. The same thing goes for the customers. We want to add a new group. We want to add the continent informations. So we can add this group. For Germany, it's gonna be Europe. For USA, it's gonna be North America. And for the rest, France, Germany, USA, it's going to be as well Europe. So that's it. All what we are doing now is adding new groups to our data. So the groups in Tableau combine similar related values into higher level categories, which can create a new dimension for your data analysis. Alright, so now let's see how we can create groups in Tableau, and there is two methods in order to do that, either by creating the groups in the data pane or directly in the view. So we're going to start with the first one, where we're going to create the continent group in the data pane. So in order to do that, we're going to go to the table customers, and based on the values from the country, we're going to create the new group. And here it's important to understand that we can create groups only on top of dimensions. So we cannot create groups on the measures. There is another feature where we can use it to group up the measures, and we call it pins. But now for the groups, we can create only on top of the dimensions, and the new field gonna be as well a dimension. So let's see how we can do that. Select the country, right click on it, and then let's go to the create, and here we have the option group. So let's select that. So now we're gonna get a new window. In order to create the group, we're gonna start first by renaming the field name. So we're gonna call this continent. And then in the middle over here, Tableau gonna list for you the distinct values inside the country. So all possible values from the datasets. So what we're gonna do, we're gonna group up France, Germany, and Italy to Europe, and USA to North America. So how we're gonna do that? So we're gonna multi-select those values by clicking Control. So France, Germany, and Italy, they are one group. So in order to group them together, we're gonna select over here the group. So once we select it, Tableau gonna put all those values underneath a new group. So we're gonna give it the name of Europe. Let's click OK. And with that, we have created now a new group for those three values. So as you can see, we can expand and collapse those values to see the details. But still, we have one more value inside the country that is not mapped yet to a group. And here what we're going to do, we're going to select it and then click on the group. And we're going to call it North America. So that's it. Now inside the continent, we have two values, Europe and North America, and they are related to those members from the country dimension. So now let's say that you want to move one of those members from one group to another group. So how we can do that? It's really easy by just drag and drop. So let's take, for example, Germany, drag and drop it here in the North America, and you will see this member now belongs to the group of North America, which is wrong. So I'm going to put it back. And that's it. This is how you switch between groups. And here we have in Tableau another option is to remove the member from all groups. In order to do that, let's select Germany and click over here ungroup. So once we do that, you will see that the Germany value is not assigned to any of those groups. So if I here collapse those stuff, you will see that Germany is a standalone value. We usually use the group other for all values that we couldn't assign to any of our groups. And here Tableau gives us a quick way in order to create this group. So all what we have to do is to click the value Germany and then click over here include other. So let's put that. And as you can see now, the value Germany is inside the group other. And with that, we have in the continent three groups, Europe, North America, and other. And now if you want to rename the groups, you can click on the group and then click over here, rename. So we're going to have it like other continent or something. Or right click on the group and then rename. That's really easy. So now what we want to do is to move Germany back to Europe. And now as you can see, the group other did disappear because it doesn't have any member. So that's it for now. We have created our groups. Let's click OK. And now as you can see on the left side, we have a new field called continent, and it is discrete dimension, and it has a special icon on the data type indicate that this field is a group. And in Tableau, if you are creating a group based on another field with a geographic role, Tableau can show both of the icons, group and geographic role, because usually the group has the following icon. So for this situation, it's going to show both of the icons, geographic role and the group. Alright, so now let's build a view based on this new dimension. We're going to take the continent, drag and drop it here on the rows. As you can see, it has two values. We're going to take the sales as well, put it in the columns. And now to see more details in the view, we're going to take another dimension, or we're going to take the whole hierarchy of the location. So let's drag and drop it here on the rows. And now as you can see, the continent is now grouping our data. So Europe for those three values, North America for USA. And as we learned in the hierarchies, we can drill down to the next values. And you know what? This new dimension, the continent, has similar information to the country and city, and it belongs to the hierarchy. So now it makes sense to add it to the structure of our location hierarchy. So what we're going to do, we're going to drag the continent and drop it on top of the country. So with that, the continent gonna be the level 1 and country gonna be the level 2. So we can use this new group as the highest level of aggregation in our structure. So we can drill up back to the continent. So as you can see, we can create new groups directly in Tableau without going back to the original datasets and do modification there. Alright, so that's what the first method on how to create groups in Tableau from the data pane. The second method is to create groups directly in the view. So let's see how we can do that. So we're going to create a new worksheet and we're going to take two measures. We're going to take the profit Let's put it here on the rows, and we're going to take as well the sales. And now we want to show all the customers as data points. In order to do that, we're going to go to the customer ID, drag and drop it, put it here on the marks, on the details. So now we have for each customer in our dataset as a data point. And now our task is we want to group up the customers based on their performance. And if you decide to go to the data pane in order to create those groups and right click on it, then we go to the groups. You will see a long list of all customers, and now creating groups based on those values can be really painful because the customer ID has high cardinality compared to the country. So instead of doing that here, we will do it directly in the view. In order to do that, we will go and select, for example, those customers, those data points, and we will get a new window. So as you can see, Tableau tells us there is 8 items that are selected, and we have the icon of the group. So if we click on that, Tableau gonna be create few stuff. So if you look to the data pane over here on the left side, you can see that Tableau did already create a group with the selected items, and it did as well the coloring, so you can see the group as well here in the colors. And on the right side we have the legends, so you can see the selected item is the blue and the others are gray. So now what we have to do is to go and rename stuff. So first of all, I'm gonna rename this group. I'm gonna call it customer group. And as you can see, the group name is like the list of all members. So it says, okay, 9, 11, 33, 5 and more. And that's because it's hard for Tableau to understand why did we select those customers and what is the group name. In order to rename the group, we're gonna go to the left side to the data pane, right click on it, and then we go to edit group. So select that. And now as you can see over here, we have our group that we just selected with the 8 members. So let's go to the group name, right click on it, rename, and we're gonna call it high performers. So that's it. Those customers has the highest performance compared to all other customers. So as you can see, Tableau did put all the other customers under the group other. So let's click OK now. And now we have a better name on the right side, and it makes sense to have a gray color for other. All right, so now we're going to go and create another group of customers with a low performance. All right, in order to do that, we're going to do the same. We're going to go in the view and select those customers with the bad performance. And once we do that, we're going to get this new window saying, okay, 9 items, and we're going to select the group. But instead of that, if you move your mouse away, you will see the window disappears. So in this case, we're gonna go to one of those data points and right click on it, and then here we have the option of group. So select that, and now what can happen, Tableau will not create a new group on the data pane, it's gonna include it as a new group inside the already existing group. So you can see here on the right side, we have new group with the color of orange, and with that we have added a new group to the customer. In order to rename it, we're gonna go to the data pane and edit the group. So let's go there. And now instead of having the list of the members, we're going to right click on it, rename, and we're going to call it low performers. Let's click OK. And now with that, we have nice namings for the groups. We can as well change the colors of the group. For example, for the low performance, we can have red. For the high performance, we can have green. In order to do that, we're going to go to the marks over here to the colors, click on that. Then we're going to select edit colors. As we said, for the high performance, so let's select this value and assign it to green. And we want for the low performance to have a red. And the color of the other going to be gray since it's not our focus. So let's click OK. And as you can see now, the data points has new colors. And another use case for the groups is that we use it as well as a filter. So we give the users the possibility to interact with our views and to focus in specific group. And now in order to do that, we're going to go to our data pane to the group, right click on it and show filter. So now we have the group as a filter, and the users can click between the groups to change their focus on which cluster they're going to analyze. And for example, if they are not interested with all those gray stuff and they want to compare the high performance with the low performance to understand the difference behavior between them, they can just remove it like this. Alright, so this is how you can create groups in Tableau using the two methods, either from the data pane, especially if you have a dimension with a low cardinality like the country. But if you have a dimension with high cardinality, like the customer ID, order ID, then you can create groups directly from the view, which is a really fast way to assign the values to specific groups. So as you can see, this feature in Tableau, the groups, is a really awesome way on how to group by your data directly in Tableau without going back to the original datasets and create the group there. Alright, so now you have the following task for you. Go to the small datasets and create a new group called classes based on the dimension product name. The first 3 products belong to the class A and the last 2 products belongs to the class B. You can pause the video right now to do the task, then resume it once you are done. Alright, so now let's quickly create this group. We're gonna check first the cardinality of the product name. So I'm just gonna drag and drop it here in the rows. And as you can see, we have only 5 values. So that means it has low cardinality and we can do it directly in the data pane. So right click on the product name and then we're gonna go to the create group, and now we're gonna call it product class. So we're gonna go and call it classes. And the first 3 members are the class A, and the last 2 members are the class B. So that's it. Let's go OK. And now we can go and check the value. So let's drag and drop it over here before the product name. And as you can see, the 3 products are class A and the 2 products here are class B. So that's it. This is really easy. Alright, so now let's summarize. Groups in Tableau combine related similar values into high-level categories, and groups can be created based only on dimensions. We cannot create groups from measures, and the group itself is gonna be a discrete dimension. So groups in Tableau are very useful to simplify your view and make it easier to understand your data by grouping the data points into clear and relevant categories. Alright everyone, so now we're gonna learn another method on how to group up the members, the values of dimensions into groups. And this time we're gonna use the cluster groups in Tableau. But as usual, first let's understand the concept behind it, then we're gonna learn how to build it in Tableau. So let's go. Alright, so cluster group is another way of grouping your data used for data clustering, which is a statistical technique to group up similar data points together. In data clustering, we have different algorithms to calculate the clusters. For example, we have the algorithm k-means, and another algorithm called hierarchical clustering, and another one called density-based clustering. And Tableau did decide to go with the k-mean algorithm since it's really simple and easy to implement. And the k-mean algorithm is widely used in data clustering. And now let me show you how the k-means algorithm works. Let's say that in our dataset we have the following data points. So first we have to define how many clusters we want to build. So in this example we're gonna go with 3 clusters, and after that the algorithm gonna pick 3 points and we call them centroids. And then it's gonna assign the data points to the nearest centroid. So for this data point it's gonna belong to the green cluster. And then it's gonna go to the next data point and calculate the length between it and the 3 centroids. And then it's gonna assign it to the nearest centroid. For this it's gonna be the red cluster. So the algorithm gonna do that for all data points and assign them to the nearest centroid. So at the end we're gonna have 3 clusters, the green, red and blue. As you can see, the k-means is really simple and easy to implement. Alright, so now in order to understand the clusters, let's have the following task. The task says to identify high-value customers by clustering them based on their sales and profits, in order to find out which customers generate the most revenue and which do not. Alright, so now in order to create the cluster group, we have to be at the worksheet page, and this time we can create the clusters from the analytics pane, and we cannot do it at the data pane. So now let's see how we can create the clusters, and we will stay with the big data source since we need a lot of data points. And here we need 2 measures. We need the profit, so let's drag and drop it on the rows, and we're gonna take the sales as well to the columns, and with that we have 2 axes, the sales and profits. But what we are missing now in the middle is the customer's data. Each customer is gonna be 1 point. For that we're gonna take the customer ID and we're gonna drag and drop it over here on the details, on the marks. Alright, so now we have the data points and each point represents 1 customer. So now in order to create the cluster, we're gonna switch to the analytics pane. So let's go over there. And if you go to the models, you will find the cluster. So it's really easy. We just drag and drop it here on the name clusters. And here we will have a very simple window. So here it says the variables for the clusters are the sales and profit. And then we have the number of clusters. And here as a default, it's going to be automatic. That means Tableau going to figure out from the data how many clusters do we need. And here as a default, we have automatic. That means Tableau going to figure out how many clusters it makes sense to create from those data points. So as you can see, Tableau did already create the cluster and it created 3 clusters. But if you say, you know what, we want 4 clusters or 5 clusters, you can go over here and define how many clusters do you need. So if we have 5, let me just move it over here to see what is going on. So we have now 5 clusters. If you want to have 2 clusters, we will have only 2 colors and so on. So I'm going to stay with the 3 clusters. It makes sense. So that's it. In this window, there is no OK or something. So we're just going to close it because Tableau going to create the cluster immediately. All right. So now we have the cluster. The question is, where do I find the cluster group? Well, if you go to the data pane on the left side, you will not find any cluster group over here because we have this information now only on the colors. So this field here is our cluster. And now we might have this information, this cluster group in the data pane in order to use it in different views. So what we're going to do, we can just drag it and drop it somewhere in the data pane. And now over here, we can see we have a new field and the icon indicates that this field is a cluster group. So now we're going to give it the name customer clusters. Alright, so now we can reuse this cluster in different views if we need. Alright, so now the next point is how we can edit our cluster. So now we have 3 clusters. How about we want to change it to 4? How we can do it? We will go to the marks over here, right click on it, and here we have the option of edit clusters. So let's select that. We will get again the same window. So in order to change the number of clusters, we will not do it at the data pane, we're gonna do it at the marks. So this is how you edit the clusters. Now, if you go over here again and right click on the clusters, you can find we have another option called Describe Clusters. So here we're going to find more information about our clusters. So let's select that. So as you can see here, we have a lot of information about our clusters. So first we have the input for the algorithm or for the clustering algorithm. So the variables are the measures that we used in our view. So the sum of profit, the sum of sales. And the next info is the level of details. Usually here we have the dimensions, and we are using now the lowest level of details, the customer ID, since each data point represents a customer. Then we have more information about our clusters. So the number of clusters we defined are 3. The number of data points, the number of customers, we have 800 customers. And then we have a table over here. For each cluster, we have informations like the number of items or the number of data points inside each cluster. So in the cluster 1, we have around 617 customers. In the cluster 2, we have 171. And cluster 3 is the lowest. We have 12 customers. The centroids of each cluster, the central points of clusters. So if you need more statistics about our clusters, we can find it inside Describe Clusters. Alright guys, so it's really fun to work with the clusters, and I found different people use different designs on how to present the clusters. So for example, one design that I see almost everywhere is that if you go to the shapes over here and then choose the filled circle, and now if you have a lot of data points, what is interesting is that to see the overlapping between those points. But now it's really hard to see it in this view, so what I'm gonna do is that I'm gonna focus about those data points. So let's select those stuff, and then we're gonna say, okay, keep only. Let's click on that. We have now like a zoom in those points. So now in order to show those overlapping in better way, in better visual, what we're gonna do, we're gonna go to the colors, and then we're gonna reduce the opacity. So let's reduce it to something like 70%. I think it should be fine. And now our visualization will just look really professional, and you can see the overlapping between data points. Alright, so there is another design that's to assign a shape for each cluster. So before we do that, I want to have again the big picture. I will remove the filter. So let's just remove the filter from here to somewhere else. And with that, we are back to original view. So what we're going to do is that we're going to take the cluster and put it on the shapes. So let's drag and drop the cluster on the marks over here on the shapes. So as you can see, for each cluster, we have a shape, we have the plus, square, and circle. And if you want to assign different shapes, what you're going to do is click on the shapes. And now we can go over here and change the shape of cluster. Let's say instead of plus for the cluster 3, we're going to have X. And let's click OK. And now instead of plus, we have X's. So this is how I usually design the clusters in Tableau. Alright, so now after we create the clusters, it's really important to interpret the outcomes of the clusters with the business. Like in one hand, we have the red cluster focus on the customers with the high profits. And in the other hand, we have the blue cluster focus on the customers with the low profits. So clustering your customers based on the sales and profit can help you to gain insights about your customers, which can help the business to target its marketing strategy very effectively. Alright, so now we have the following task for you. The task says to identify the top selling products by clustering the products based on the quantity and the profits. Create 5 clusters using the big data source. You can pause the video right now to do the task, then resume it once you are done. Alright, so now let's create the cluster for the products. Here we need 2 measures. We have the profit and the quantity. So let's have first the profits. We can drag and drop it here on the rows, and then we're going to take the quantities on the columns, and now we need the dimension to define the level of details, the data points, and here we're going to use either the product ID or the product name. So I will go now for the product name. So drag and drop it on the details. Alright, so now we have everything. We have the measures and the dimension, and we're gonna go and create the cluster. So we go to the analytics pane, and then we take the cluster, drag and drop it over here. And Tableau did create here only 2 clusters, but the task says 5 clusters. So we're gonna go over here and define 5. Alright, so that's it. Now we have 5 clusters for the products. Let's close this. So clustering the products based on the quantity and the profits can help you to gain insights about the product portfolio, and the business can use it for many stuff. For example, to optimize the inventory management and make strategic decisions about the product development and marketing. So this is really amazing. Alright, so now let's summarize. The cluster group in Tableau is a statistical technique to group up similar data points together in clusters. The cluster algorithm used in Tableau is the k-means, easy to implement and as well easy to understand. Clustering in Tableau is one of the main features and very powerful, since Tableau is the only tool, the only BI tool that can plot endless amount of data points. Because other BI tools like Power BI, they always like make limitations on the number of the data points that you can see in the visualization, which can make it really impossible to create clusters in Power BI. And data clustering in visualization is a very powerful tool for data analysis and pattern recognitions to help the business and the organizations to be data driven, which means to make better decisions using the data. On how to group up the members, the values of dimensions into groups. But this time we're gonna use the sets in Tableau. It is very similar to clusters. And as usual, we're gonna start first with the concepts, then we're gonna learn how to build it in Tableau. So let's go. Alright, so now let's say that we have the following data points in our visualization. We can use datasets to group up those data points. So sets can define your data based on specific criteria or selection into two groups of data. The first group, we call it the in group. In this group, you're gonna find all the data points that are included in the subsets of data. These data points are the members of the set. And the other group is the out group. This group contains all the data points that are not included in the subsets of the data. So that means the data points in this group are not the members of the set. So the sets in Tableau divide our data into two groups, the in and out groups. So when do we need sets and why it's important? Well, we can use this subset of data to do focus analysis in specific scenario and as well to compare this subset with the remaining data. For example, we can make a subset of the top 10 customers in our datasets based on the sales and compare the subset with the remaining customers in order to understand their behavior and what makes them on top 10. So it's really amazing feature in Tableau to understand your data and to make focus analysis on specific scenario. And in Tableau, we have different ways to create the sets. The first option is to create a fixed set, and that's by using a manual selection. And the other way is to create a dynamic set based on specific criteria. And here we have two ways to create the dynamic set, either using condition or using ranking, top or bottom. And now the last method of creating sets in Tableau is by combining two sets. And it can create new combined sets. So since we are combining data together, it's like the joins. Here we have four options: inner, left, right, and full join. And here the output gonna be a new combined set. So that's it. Those are the different methods in order to create sets in Tableau. So let's have quickly some simple examples in order to understand those methods. Alright, so now back to our 5 customers, and now we're gonna create different sets using different methods. We're gonna start with the first set. It's gonna be fixed sets using a manual selection. So here we're gonna go and manually select which customers are inside the subset and which customers are outside. So here we're assigning two values, in and out. So for example, we're gonna say John is inside the set and as well Peter, but the rest gonna be out. So Martin, George, and Maria gonna be outside of the set. So as you can see, we just manually selected which customers are in the set. So let's move to the second set, where we're gonna create a dynamic set using a condition where the sales is bigger than 400. So here we will not select anything manually. We will just define the rule for Tableau, and Tableau gonna do it automatically for us. So Tableau gonna scan here all the customers and start assigning the values in and out. So the first customer is Maria, does not fulfill the condition, so it's gonna be out of the set. Next we have the second customer, John. He has high score, so 900, it fulfilled the condition, so he is a member of the set. The same goes for George, 750, Martin as well, but Peter don't have any score, so he does not fulfill the condition. He will be out of this. But Peter don't have any score, so he does not fulfill the condition. Peter is out. So using this condition, we have 3 customers in and 2 are out. So now what makes dynamic sets very important and efficient is that, let's say in the next days, those scores of the customers did change. So what's gonna happen after you refresh your data in Tableau? Tableau gonna recalculate the condition and assign new values if something changed. So there is dynamic and everything gonna be done automatically. And now let's move to the third one. We have dynamic sets, and now we're gonna use the top 2 customers, which means the top 2 scores gonna be inside the subsets and the rest gonna be out. So if you have a look at the data, you can see John and George has the highest scores between the customers. So those 2 customers gonna be in and the rest gonna be out. And again, everything here dynamic and automatic. We just specify the rule and Tableau gonna do the rest. Alright guys, so those are the 3 methods to create a set. And next we're gonna go more advanced, where we're gonna create a set from combining 2 sets. So here we're gonna take the following example, where we're gonna create a new combined set by combining set 1 and set 3. So here it's really important to understand that the calculation of this new combined set gonna be based on the output from the set 1 and set 3. So Tableau will not check the table customers, it's gonna check only the output from the sets. And here we have to configure the combined sets, and we have 4 options. It's something similar to the joins, but not exactly like the joins. So let's go through those options one by one. The first option says all members in both sets. So that means the customer gonna be a member of the combined set if the customer is at least a member of one of those 2 groups. So let's check our customers. Maria is not a member in set 1 and set 3, so it's gonna be not as well a member of the combined group. And the next customer, John, is a member of both groups, so that is more than enough. So he's gonna be as well a member of the combined set. And George is a member of one of the sets, so he's gonna be as well in. Martin here again is like Maria, he's not a member of set 1 and set 3, so he's gonna be as well out. And then the last customer, Peter, he is a customer of one of those 2 groups, so that's gonna be enough to be a member in the combined set. So as you can see with this option, it's gonna be enough for the customer to be a member of one of the 2 groups to be in the combined group. Alright, so now let's move to the next option. It says shared member in both sets. So that means to be a member in the combined set, the customer should be a member of both sets. So it's not like the first option, it's enough for the customer to be one of the sets, the customer has to be in both sets. So let's check our customers again. Maria is not a member of both sets, so Maria gonna be out. But next we have the customer John, he is a member of both sets, so that means he fulfilled the requirements, and John gonna be a member of the combined set as well. So now as you can see for the other 3 customers, none of them fulfill this requirement. So that means none of those customers gonna be inside our set. Well, this option is very restrictive. Alright, so now let's move to the next one. It's gonna says set 1 except shared members. So what this means, we're gonna have all the members from the set 1, but they should not be a member in the set 3. So let's check the customers. Maria is not a member in both of them, so she's gonna be out. And now we come to John. John is a member of the set 1, but he is as well a member of the set 3. Well, this time John will not be a member of this group because we are saying except shared members. So that means John this time gonna be out. The next one, George, is not a member of the set 1, so automatically gonna be out. The same goes for Martin, he's not a member of the set 1. But now if you check Peter, he is the only one that's fulfilled this requirement. Peter is a member of the set 1 and not member of the set 3. And this is exactly the requirement for this group, so Peter gonna be a member of the set 3. And this is exactly the requirement of this option, so only Peter gonna be a member of this group. Alright, so now let's move to the last one. It's exactly the opposite. So it says set 3 except shared members. So the requirements for the customers to be a member of this combined group is to be a member of the set 3 but not a member of the set 1. Alright, so now let's check our customers. I really feel bad for Maria, she is not a member of any of those sets. Like if your name is Maria, I'm really sorry for that, it's not intended. But now it's really too late, I already recorded. So sorry for that, next time I promise you I'm gonna make better examples. But for now Maria is out as well in this group. The same here goes for John. John is a member of set 3, but John is as well a member of set 1. So he does not fulfill the requirements. John gonna be out. Now if you look to the customers, George is the only one in the set 3 and not in the set 1. So only John gonna be in this group and the other 2 are out. Alright, so with that we have covered all the scenarios, all the methods that we have in the Tableau sets. Alright guys, so now let's see how we can create sets in Tableau. We can create it in the worksheet page, we cannot do it at the data source page, and we can do it either at the data pane or in the view. So now we're going to create different sets using different methods. But first let's create the view, so we need the customer ID. By the way, instead of drag and drop, you can double click on the fields and it's gonna be in the rows. We need as well the first name, so double click on the first name. And we would like to have the scores as well, so drag and drop the scores at the ABC. So now we're gonna create the fixed set using manual selection. So in order to do that, we're gonna go to the customer ID over here on the data pane, right click on it, and then we go to create. And over here we have sets. As you can see, the sets has the icon of joins, but it is not joins, it has just the same symbol. So let's click on that. And now we have a new window. So let's see what do we have over here. So we have first the name of the set. So let's call it set1 and fixed. And now we have over here 3 tabs: General, Condition, and Tops. As you can see, those are the different methods of creating sets in Tableau. The General tab is actually the manual selection, the Condition, as you know, the dynamic set, and the Top as well is a dynamic set. So now we're gonna go with the first one. We're gonna start with the General manual selection. And now here in the middle, we have the list of all customers in our datasets, and we have to go and start selecting manually which customers are in and which customers are out. So in our example, we selected the customer 2 and the customer 5 to be the members of the in group. And anything that you are not selecting gonna be on the out group. So that's it, the customer 1, 3, 4 are out. So let's go now and click OK. So now let's see what happened on the data pane. We have a new field. It's gonna be discrete dimension. And since it's set, it's gonna has the following icon. As I said, it's like the icon of joins. So now let's see the values inside this field. Let's drag and drop it over here. And now as you can see, we have only 2 values, out and in. It's like Boolean data type. We have true and false. And here as well in the sets, we have only 2 values. So we selected the customer 2 to be in the set and as well the customer 5 to be in the set. The rest gonna be out. So this is how you can create sets in Tableau using manual selection, and it's gonna be fixed. Alright, so now we're gonna go and create a dynamic set using condition. Our example was the customers with the score higher than 400. So let's go again to the left side, right click on the customer ID, go to create and then to set. So let's call it now set 2 and we're gonna call it condition. So since we are making now a condition, we're gonna go to the tab condition over here. So now we're gonna go and specify for Tableau the rule to decide which members are in and which members are out. The rule says score higher than 400. So let's define that. First, we have to select this by field. So our field is a score, which is correct. And then the operation over here is not equal. It should be higher than 400. So we have to specify the value over here and that's it. If the score is higher than 400, the customer gonna be in, otherwise it's gonna be out. So now let's go and click OK. And as you can see, we have another dimension on the data pane called set2. So double click. So let's check the values. The score over here 350, which is out, 900 in, 750 in, 500 in, and null, it's out. So as you can see, it's really easy to define the dynamic set. We have just to provide the rule and Tableau can do the rest. And if tomorrow we have different data, the set member gonna change. So now we're gonna create another dynamic set using the rank. So in our example, we had the top 2 customers gonna be in and the rest gonna be out. So again, we're gonna go to the data pane, right click on the customer ID, create, then set. Let's give it a name. So it's gonna be set 3 and rank. So now we're gonna go to the third tab over here to the top. So let's go there. So for this example, we're gonna use the score to rank the customer. So the highest 2 scores gonna be in. So in order to do that, it's really easy. We're gonna define it here by field. And here in ranking, we have top or bottom, as you can see. So we're gonna stay with the top. And next we have to define what we are selecting. Top 2 customers, top 10, top 5, top 20. So here we have to go with a 2 and by score. So we are using the score, everything is correct and that's it. So this is how we define the rule and Tableau gonna do the rest. So it's really logic if you just read it top 2 by score. Alright, so that's all. Let's go and select OK. Again, as you can see, we have the set over here in the data pane. Double click on it. And now let's check the data. As you can see, John and George, they have the highest scores. That's why they are in and the rest they are out. So as you can see, sets are really easy in Tableau. Alright, so now we're gonna go and make it a little bit complicated where we're gonna create combined sets. So we're gonna go and combine set 1 with set 3. So in order to do that, we're gonna go again to the data pane, but this time we're gonna start from the set. So let's go to the set number 1, right click on it, and then we have here an option called create combined sets. Let's click on that. So as you can see, we have here a new window for the combined sets. First, let's give it a name. So it's gonna be set 4 and combined. So first we have to define the 2 sets. So we have here the set 1 since we started from it. And then on the right side, if you click on it, you will get the list of all sets available in the data pane. So we have the set 2 and set 3. So we're going to go with the set 3. Alright, so with that, we have defined which set's going to be combined. But now we have to define for Tableau how the data going to be combined. So here we have 4 options. The first one is going to be all members in both sets. The second one, only the shared members on both sets. And the next one is going to focus on the set 1. And the last one going to focus on the set 3. So for this example, we're going to go with the shared members in both sets. So let's go and select that. And as you can see here between the sets, the icon did change as well. Alright, so now everything is ready. Let's click OK. So here again on the data pane, we have a new field, new dimension. Let's see the results. I'm going to go and double click on it. So now let's see the results. We are combining the set 1 over here with the set 3. So here if you go and search for the shared member, it's going to be only the customer 2 since it is in the set 1 and as well in the set 3. So as you can see, we have only one member in the combined set, and that is the customer John, because it is the only shared customers between the two sets. So it's really not that hard. You just have to pay a little bit attention to which combining option you are using. Alright guys, so far we have learned how to create the sets from the data pane using different methods. Next we're gonna go and learn how to create the sets directly from the views. Alright, so now we're gonna go and create a new view, and it's gonna be something similar to the cluster group. So we're gonna have the two measures, profit and sales. So let's go and select them. So double click on the profit and double click on the sales. We have now the two axes. What we are missing now, the customers. So in order to add the data points, we're going to go to the customer ID and double click on it. So now we have our view, and we're going to go and create the set directly from the view. So here it's very similar to the groups. We're going to go and select which customer is going to be the member of our set. So in this example, we're going to go and select the customers with the high performance. So all what you have to do is to select like this. Let's go for those customers. And again, here we have this new window. Last time we have created the group, but this time we're going to go and create a set from those customers. So click on that, and then we have to select this create set. So let's go and select it. So now we have a new window, and as you can see, we cannot define conditions or any dynamic sets. It's gonna show us a list of all customers that we have selected in the view. And the only thing that we can do over here is to check, did we select all the customers correctly? And if we've done any mistakes, we can go and remove the customer. So now let's give it a name. I'm gonna call it set customers high performers. So that's all for now. We're gonna go and hit OK. So let's select that. So now as you can see, nothing changed yet in our view. We have now a new field on the data pane called set. So we just created new set directly from the view. And now quickly I want to show you something. If you are selecting group like this, and let's say the window here disappeared, what you can do, you can go to any of those data points, right click on it, and then here the last option is create set. So this is another way how to create a set directly from the view. Alright, so now we have the set, and you might ask me, okay, what we can do with it? Well, we can do many things with the set now. So first, we can highlight it in our view. So in order to do that, we're going to take the set from the data pane and let's just put it on the colors. And now we can quickly see which members are in and which members are out. So here, as you can see, Tableau always uses the color gray for the members that are out of the set. And of course, you can change that by going to the marks. So if you go over here, then we go to the edit colors, and you can define over here the color of in and the color of out. But for me now, the colors are okay. So let's click OK. So with that, you are highlighting subset of your data for the end users. Alright, so the other use of the sets inside our view is that to focus on specific subset. So currently we are showing all the customers, the in and the out. So how to filter the data only for the customers that are member of the set, only for the in group. In order to do that, we're going to go to our set, right click on it, and here you can find two options. So as you can see, by default, we have show in out of set. That means we are showing everything. But now we have another option called show members in the set. So that means we're going to filter the data and we're going to show only the members inside our set, the in group. So let's go and select that and see what's going to happen. So as you can see now, Tableau remove all the customers that are outside of the set, and we can see on the view only the members of the set. So this is really quick way on how to filter your data and to make a focus in specific scenario. But now you might say, you know what, let's give this option to the users. So let's have the audience, the users decide in which subset they're going to focus on. This is going to make your view more interactive and dynamic. So in order to do that, we're going to offer the set as a filter. So let's see how we can do that. First, we have to show all the data points in our view. So we're going to switch that back. Let's go to our set, right click on it, and we're going to go and select show in out of the set, show everything. So let's select that. And next we're going to offer the set as a filter. So go to our set again, right click on it. And here we have the option of show filter. Let's select that. And now as you can see on the right side, we have the two options in, out, and all. So now we have different scenario. If the users wants now to see the whole big picture, all customers, they're going to leave the filter as it is. But if we have different scenario where they want to focus on the subset, on the customers with the high performance, all what they have to do is to deselect out in the filter. So let's go and do that. And now as you can see, we are focusing on the subset of the group in, only the members in the set. And for some other reasons, another users want to focus on the groups that are outside of the set, maybe to understand their behavior and so on. So they're gonna deselect the in and select the out. So now we are focusing on the group that are outside of the set. And again, if you want to see the whole big picture, you're gonna select both of them. So I really prefer to give this option to the users to decide in which subset they're gonna select and they're gonna focus on, because with that you are covering many scenarios in only one view. Alright guys, so now with the sets in Tableau, we can go a step further where we're gonna give the full dynamic to the users and they're gonna have the option of defining which customer is gonna be in the set. Because so far what we have done is that by creating the views, we defined everything. So we defined which customer is gonna be in and which customer is gonna be out. But now instead of predefining it, we're gonna give the options the full dynamic of defining the whole set. So let's see how we can do that. So in order to make the set dynamic and interactive, we're gonna add an action to our worksheet. I will dedicate later a full tutorials on the actions and the interactivity in Tableau, but now let's just learn how to add an action for sets. Alright, so in order to do that, we're gonna go to the main menu in Tableau to the worksheet. So select that, and then here we have actions in Tableau. Let's go there. Now I will not go in details explaining all the options that we have in the actions, because here we have way more than sets, we have a lot of things. So now just follow me, we're gonna go to the add action over here, and then we have the option here, change sets values. So that means the actions of the users gonna change the values inside our set. So let's go and select that. Now we have to give an action name, so we're gonna call it action change set, and now we can select in which worksheets this action can be applied. So now if you go over here, you can see the list of all sheets that we have in our whole workbook. So now I want to apply this action only on this worksheet, so everything is fine. And now here we are defining the behavior of the user. So now the question is when the action going to be triggered, either by hovering on the mouse or by selecting the data points or by drop down a menu. So I will stay with the default. Let's have the user clicking on those data points. Alright, so now we're going to define the target set, which set's going to change once we do the action. So let's see what do we have here. So as you can see, we have two data sources. In the tutorial, we created in the small data source 3 sets, and in the big data source, we have created only 1 set. Once the action is triggered, the values of this set should be changed. So let's select that. And now we are coming to the interesting part, but first, some coffee. Okay. So here we have 2 types of actions with the mouse. So first, let's check the left side. What's gonna happen when we select a data point? The first option gonna say assign values to set. So that means it's gonna create completely new set from what you selected. The second option is add values to set. So Tableau gonna hold the old values and everything that you are selecting gonna be added to the set. And the last option is anything that you are selecting gonna be deleted from the set. So here it really depends on how do you want the users to interact with the view. So either you want them to create completely new set, so you're gonna go with the option 1, or you want to predefine a set and you want them to extend it by adding new members to the set, so you're gonna go with the option 2, or you want the users to start removing members from the pre-existing sets. I would say let's go with the option 2, where the user is gonna add members to predefined set. Alright, so that is for the left side, what's gonna happen once the user starts selecting, and on the right side, what's gonna happen once the user starts moving away from the selection. So here the first option is to keep the set values, second is to add all values to the sets. So that means once the user start moving away from the selection, all the members, all the customers gonna be in the in group. It's gonna be inside the set. And the third one is exactly the opposite. What's gonna happen? All the data points gonna be outside of the set. So I think both of them are extreme. We're gonna leave it as it is. Keep set values. So now let's skip those options and let's see what can happen in the view once we start selecting. So let's go with OK. So as you can see here, we have our new action. Let's click OK. And now let's go inside the view and start selecting stuff. But before that, I want to change the shape of those data points to be more clear. So let's go to shapes and use the fill circle. Alright, so now I'm not selecting anything. Like if I move my mouse over here, you will see nothing gonna change. But the action here is to select, so to click on the data point. So let's click on that. Let's move away. So now you can see this member is blue. That means it is in the set. And anything I'm clicking on those data points gonna be inside our set. Or we can go over here, for example, and select all those stuff in one time. So now anything that I'm selecting in the view, as you see, it's going to be included in our set. So with that, we are going full dynamic and we give the option for the user to define which customer is in and which customer is out. Alright guys, so with that, we have covered everything about the sets, how to create it as a fixed, dynamic, from the data pane, from the view, how to add actions to it, how to add it to filters. This feature in Tableau is really great. Alright guys, so now let's summarize. The sets in Tableau gonna divide your data based on specific criteria or selection into 2 groups. So we have the in subsets, it's going to contain all the members inside the set, and the out subsets, it's going to contain all members that are not included in the set. The sets is very important feature in Tableau since it's going to allow your users to focus on subsets of your data and to compare it with the remaining data. And sets are a great way to add dynamic and interactivity to your views by giving the options for the users to define in which subset they're going to focus on. Alright guys, so far we have learned different methods on how to group up the values of dimensions into groups, but now we will learn how to group up the values of measures into groups. And for that we're gonna learn the bins in Tableau. And as usual, let's first understand the concept behind the bins, and then we're gonna learn how to build it in Tableau. So let's go. Alright guys, so before as we learn dimensions and measures, we learned the secret formula of building new views, and that is measure by dimension, like sales by category. But sometimes we have to build view from two measures, so it's gonna be measure by measure, like profit by sales, quantity by profit, and so on. One way to do that is by converting one of those measures to bins. So we will have profit by sales bins and quantity by profit bins. So what is bins? Bins divide the data into groups of equally sized containers, resulting in systematic distribution of the data. And we can use those bins to create charts called histograms. So histogram gonna classify your data into different bins and then counts how many data points do we have inside each of these bins. And in histograms, we usually use the bar chart to visual the data. Alright, so now let's have an easy example in order to understand the bins and histograms. Alright, so now let's have the following data. We have 10 customers and with their scores. The scores are like points that the customers collect. And now we want to count how many customers fall within a range of scores. For example, how many customers do we have in the range between 0 and 30, 30 and 60, and so on. So first we have to create bins. In order to create bins, we need few informations, like what is the highest value in the scores, so it's gonna be the first customer, the 63, and what is the lowest value in the scores, it's gonna be the 0. The next value that we have to define is the size of the bin. So for example, here we're gonna take the size of 30. And now we have all the information that we need in order to create the bins. Don't forget they are equally sized. So what that means, so the first bins that we have is between 0 and 30. It starts with the lowest value, the 0, and the size should be 30. That's why we have the range between 0 and 30. So this is our first bin. The next one gonna be between the 30 and the 60. Again, as you can see, the size is 30, and now the last bin gonna be between 60 and 90. And with that, we're gonna stop because with the last bin, we can cover the highest value. So with that, we have created from the measure score an equally sized bins. And now after we created our bins, we're gonna go and count how many customers, how many data points do we have inside each bin. Alright, so now let's start counting the customers for each bin. Our first bin starts from 0 to 30. So let's see how many customers do we have inside this range. So the first customer is out, we will not count it. The second one is inside the range. So we have 1 customer, 2 customers, 3 customers. This customer is out of the range, the same over here. So here we have the first customer. This customer is out. We have the customer number 5, and that's it. So we have 5 customers between the 0 and 30. Alright, so now let's move to the next bin. How many customers do we have that their score is between 30 and 60? Alright, so now let's start counting and scan our table. I think all those values are out. We have this customer that is inside this range. Then we have the 45 and as well 55. So we have 4 customers, their score between 30 and 60. So this is our second bin. Let's move now to the last bin. So we have the range between 60 and 90. And now let's count how many customers do we have inside this range. So we have 10 customers, we have already 9, so I think we have only 1, and that is the customer number 1. And all other values are not in this range, so we have 1 customer. And that's it. With that, we have created a histogram for the scores. We just have to create the bins and count how many data points are inside each of those bins. And we call those blue bars as bins, and each bin has a size. And now let's say that we want to define another value for the size of the bin, and we take the value 10. So what gonna happen? We're gonna have more bins. So the first one gonna be between 0 and 10, the next is 10 to 20, 20 to 30, and so on. So it makes sense. If you define smaller size for the bins, you will get more chunks from the data. So instead of having 3 bins, now we have 7 bins. And as you know, after creating the bins, we're gonna count how many customers do we have inside each of those bins. So if you go and start counting, you're gonna have the following histogram. So as you can see, what is defining the score is the lowest and the highest values inside our data, and as well the size of the pins. So as you can see, using the pins, we created different groups from a measure. And now you might ask me, why do we need histograms? Why they are important? Well, if you compare the table on the left side with the visual on the right side, in the histogram you can quickly identify trends and patterns in the distribution of the customers. Like you can see quickly that most of our customers have the score between 0 and 30. So this type of chart gonna help you quickly understand whether everything is okay or you have to improve in certain areas. So you can define new strategies and make better decisions using the data. Alright, so now let's see how we can create pins and histogram in Tableau, and we can do that only on the worksheet page. We cannot do it at the data source page, and there is two ways in order to do that. Either we create pins in the data pane, or we can create pins in the visualization. So let's start with the first one. So now we're going to create a histogram for the customer scores, and we're going to stay with the big data source on the left side. We're going to go to the data pane and we need the score. So right click on it, and then we go to create, and here we have the option of pins. So let's go and click that. So now we have here a new window to create the pins. The first one, we have the field name. We're going to leave it as it is. The second option here, we have the size of pins. And here as a default, Tableau going to follow specific mathematical equation in order to find the suitable size of pins. But if you don't want this value, you can go and change it. So for example, let's go with the value of 20. And after that, we found information about the range of values. So what is the minimum value and the maximum value that we found inside the field score and the differences between them. So for now, that's all. We're going to have the size of pins of 20, and let's hit OK. And now if you check the data pane on the left side, you can find a new field called score bin. It is a dimension because it has a finite number of values, and the score gonna stay of course as a measure. So let's check the values inside our new field. So let's drop it here on the rows. And now as you can see, we have the pins and the size of each pin is 20. Okay, so now so far we have the pins from the score. The next step in order to make a histogram is to get the count of the customers. So now let's use this measure, the customer count, drag and drop it here on the view. And then I have to switch between them so it looks like a histogram. So with that, we have our histogram, but we are not there yet. To make it look like a real histogram, we have to have the pins as continuous. So if you check the score bin on the left side, you can see it is a discrete, it is a blue color. And now we're gonna go and convert it to continuous. So right click on it and convert to continuous. Let's click on that. And it's still on the view as a discrete, so we have to convert it as well here in the view as a continuous. So with that, we have created a histogram in Tableau. I'm gonna add the final touch where I'm gonna add the values for each pin. So we go to the labels, show mark label, and now I'm going to change as well the coloring in our histogram. So I'm going to take the score bin and put it in the colors. Let's do that. We are still not there. I would like to have the bin with the highest number of customers to be darker. So in order to do that, we're going to go to the customers, edit color, and then we're going to go over here and reverse it. Click OK. Now I'm happy. This is how I usually present the histograms in the project. And now once we have the histogram, we have to discuss it in order to understand the data. So usually we search for peaks, for valleys, or any outliers that stands out. And for histograms, there are different shapes with different interpretations. And the shape of our histogram that we have called skewed to the right. Skewed to the right means that the histogram on the left side has the highest peak, and then the frequency of the data going to be descending as you go to the right, and on the right side you're going to have the lowest frequency of the data points, which is not really good in this example. That means we have a lot of new customers that didn't collect yet any points. So the histograms are really powerful to see the distribution of your customers in one click and to quickly understand whether there are issues in your business or if you find any new trends. So now for this example, we have decided that the size of the bin is 20. Let's say that you want to change the distribution and you want to change the size as well. So in order to do that, let's go to our field, right click on it, and then we go to the edit. So let's select that. And here we can go over here and change it to 10. Let's click OK. And now as you can see, we have more pins and more details about our data. So now you might ask me, I want it to be more dynamic and I want to give the users the option of defining how many pins do we have. And for this, we're going to use another feature called parameters, which is going to be in the next tutorial. Alright, so now so far we have learned how to create pins from the data pane. There is another way to create pins and histogram in Tableau, which is way easier than what I showed you. We can do that directly from the visualization. Let me show you what I mean. So let's create a new worksheet. And let's say that I want to create a histogram from the sales. So in order to do that, we're gonna go and take the sales and put it in the rows. And then we're gonna go over here on the show me, and we have predefined visualization from Tableau called histogram. So the requirement for this visualization is only one measure. So once we click on that, you will see that Tableau did everything. If you check the data pane on the left side, we have already a bin or a dimension called sales bin with the role of continuous. And of course, Tableau gonna suggest the size of the bins. You can go and change that, of course. But as you can see, it's really easy. We just took one measure in the view and click on the histogram. The rest gonna be done from Tableau. And this is exactly the power of Tableau in the visualization. Alright guys, so now let's have a summary. Bins gonna divide your data into equally sized containers, which gonna result in systematic distribution of the data. And bins are the method of creating groups from measures. So that means we can create bins only from the measures, we cannot create it from dimensions, because dimensions are already bins. And bins themselves are dimensions, and it's better to convert it to continuous dimension to be used in histograms. And one limitation in Tableau is that you cannot create bins from calculated fields. And the main purpose of having bins and histogram is to quickly identify patterns and trends in the distribution of your data. Alright guys, so that's all for the bins and histograms. And with that, we have learned everything about how to organize and customize our data in Tableau, and we are done with this chapter. Next, we will learn in Tableau how to filter your data using different techniques at different layers. Tableau filters. In Tableau, we have many different types of filters for different purposes, like optimizing the performance or as well for your users to explore your data. That's why it's very important to understand them and the differences between them. So that's why first we're gonna start by understanding the concept behind the different types of filters in Tableau, and then we can learn the different methods on how to create all those filters in Tableau. Moving on, we can learn the many different options on how to customize the filters in Tableau, and at the end I'm gonna share with you many tips and tricks, best practices of using filters in Tableau that I usually follow in my projects. So let's start with the first topic, where we can understand the concept behind the different types of filters in Tableau. So now let's go. Alright guys, so now we're gonna talk about the filters in Tableau, but first, as usual, we have to understand the concept behind them, and then we're gonna learn how to build filters in Tableau. So let's go. Alright, so now we're gonna start with the question, what are filters? Filters means to remove or select a subset of the data for different purposes and use cases. And in Tableau, we have the following reasons or use cases for filters. The first use case for the filters is to reduce the size of your data. Reducing the size of your data inside Tableau gonna improve and optimize the performance of your dashboards. Especially if you are dealing in the project with a huge data source, reducing the size of such a data source gonna mean reducing the processing time inside Tableau, which gonna lead to optimized response time in your visualizations. So this is one of the reasons why we use filters in Tableau to optimize the performance of our dashboards. The second use case of filters is interactivity and analysis. We usually offer a set of different filters for the users because different users may have different goals or may be interested in specific aspect of the data. So that means allowing the users to filter and to focus on subsets of the data gonna help in better analyzing and understanding of the data. And the third use case for the filters is hiding sensitive informations. Data security is becoming a very important topic in each project, as now many people are working with the data security is becoming a very important topic. And in Tableau, we can use filters to restrict the sensitive data or to hide it from the viewers to make sure that we are protecting such a sensitive or confidential data from being exposed to the others. And the fourth use case for the filters is data access control, row-level security RLS. So this means that we can use the filters in Tableau to limit the access to data of the users based on the role and the permissions. Because in real projects, you cannot just go and build visualizations and share it with everyone. Instead, you have to protect your data and to have some data restrictions. Like for example, you're gonna have users like sales employee, they should not see the data like managers. So in order to protect your data and implement the row-level security in Tableau, you can use filters. So as you can see, filters are really useful in data visualizations. And in Tableau, we have 6 different filters for different purposes and use cases. And I group them under 2 categories. The first group of filters, they're gonna optimize the performance. So we have under this category the extract filter, data source filter, and the context filter. And we have another group for the interactivity and for analysis. And underneath this group, we have the following filters. We have dimension filter, measure filter, and table calculation filters. And now I'm gonna go and explain them one by one. Alright, so now in order to understand how the different Tableau filters work, let's have a quick recap on how Tableau processes the data through different layers. Let's go. First, you connect your original data into Tableau data sources by either having an extract connection, where you're gonna load an extra copy of the data inside Tableau, or you can use a live connection between your data and Tableau data source to get data on demand. Then you might have different worksheets connected to the data source, and for the visualizations, they're gonna send a query to the data source, and then the data source gonna respond by sending the result data back to the visualizations and to the worksheet. So as you can see, your data is moving through different layers, different stations, and if you are not using any type of Tableau filters, the whole amount of data gonna be moved and processed from one layer to another layer. So for example, and those are just numbers to explain the concepts, we have in the original source of our data 30,000 records. That means the whole amount of data gonna be exist as well at the data source level. So there we're gonna have as well the same number of records, 30k, and then the same amount might be as well the results of your queries. So we're gonna have as well 30k records in the visualizations. So we might be in a situation where the source of our data might has a lot of unnecessary data. So it's gonna be really wasting resources and performance in Tableau if we are going to process the whole amount of data in each layer. So what we're gonna do, we're gonna go and apply different types of filters as your data is moving from left to right, from the sources to the visualizations. The first type of filters that we can use called the extract filter. You can apply the extract filter between the source of your data and the Tableau data source. You can use this type of filter if you are using the extract connection. So that means you cannot use the extract filter for the data sources using the live connection. So the extract filter will be used to filter the data before it even enter the Tableau data source. So for example, if we are using the extract filter, instead of having the whole amount of data in the data source, we might have only 20k of records. So the main purpose of the extract filter is to optimize the performance of loading data into Tableau. Sometimes you might be in a situation where loading the extract or refreshing the extract in the Tableau data source taking very long time. Here usually we go and create the extract filter in order to get rid of all unnecessary data and remove it before it even enters Tableau. And another benefit is optimizing the performance of your visualizations, because we're gonna have less data, less processing time in Tableau, and that's gonna result in better response time in your visualizations. So the main purpose of extract filter is to optimize both the loading time and as well the response time. And now let's move one step to the right side. We have another filter, we call it the data source filter. So you can apply this filter between the Tableau data source and the worksheets. So here again, the worksheets are sending queries to the data source, but this time the data source will not respond by sending everything, the whole data, but instead here the data source gonna filter the data first and then send the results. So here instead of sending 20k of records, here Tableau might send like around 10k of records. So here again, the main purpose of the data source filter is to reduce the size of data. So that means, and you know that already, having less data means less processing time in Tableau and better response time in the worksheet in the visualizations. And here we have another use case for the data source filter is to hide sensitive informations from the worksheets from the viewers. Alright, so now the question is, what are the main differences between the extract filter and the data source filter? Those two filters are really similar, but still we have some differences. The extract filter, as the name says, it could be applied only on the extract connections, while the data source filters could be applied in both extract and live connections. Extract filters could be found only on the Tableau desktop version, but the data source filter, we can find it in both Tableau desktop and Tableau public. And the main purpose of the extract filter is to optimize both of the performance of loading the data and as well the response time in the visualizations, while the main purpose of the data source is to optimize the response time in the visualizations and as well to hide sensitive informations from the viewers from the worksheets. Alright, so now we're gonna move one more step to the right side to the next station, where the data is now inside our worksheets, and here we can use a very unique Tableau filter called the context filter. In Tableau, if you create a context filter, what you are doing is creating an additional layer inside the worksheets, where Tableau gonna take the result data from the data source and create a new optimized temporal table based on the filter inside the worksheet. And then the visualization is gonna get the data from this temporal new table or subset. And here the downside of the context filter is we are losing performance because Tableau gonna spend resources and time in order to build this temporal table. So now you might ask me, why do we need a context filter if we have a data source filter? We can easily use the data source filter in order to reduce the size, and with that Tableau don't waste any resources or time in order to build this layer, this extra table. Well, the answer for that is flexibility, because once you apply a data source filter, you are filtering all the worksheets that are connected to this data source. And in some scenarios, you cannot use the data source filters because you have different requirements and different focus in each worksheet. So you cannot set up one filter that is suitable for all worksheets. And here comes the power of the context filter, where you can fulfill all the different requirements by defining different filters for different worksheets. So you are flexible with the requirements, and at the same time, you are reducing the size of the data to optimize the performance of the visualizations. And here you can go and decide for each worksheet whether you want to reduce the data using context filter or you want to have the whole data. So having this option gonna give you a lot of flexibility. So for example, in the worksheet number 1, we could use a context filter where we can reduce the number of records to 7K. And in the second worksheet, we could use a different context filter with different criteria where we can reduce the number of records to 5K. So the context filter is a really unique feature in Tableau, but don't forget we have here a trade-off between the flexibility and as well losing some performance because Tableau have to create those temporal tables. So now by checking the big picture, that's how the first category of the filters works in Tableau. We have the extract filter, data source filter, and the context filter, and they share the same goal, to reduce the size of the data in order to optimize the performance of the visualizations. These filters are usually created from the Tableau developers and will not be offered for the users in the visualizations. And that brings us to the second category of the filters. We have the dimension filter, measure filter, and the table calculation filter. We usually offer these filters to the users to give them the power of slicing and dicing the data to focus on specific subset of the data. So these filters usually exist in the visualizations and they share the same purpose, to enable users to do analysis and to have better understanding of the data. And it's better to explain those three filters directly in Tableau. And now by looking to the big picture, you can understand that as we are moving from left to right, the importance and the priority of the filters are changing. For example, the most important filter is the extract filter and as well has the highest prio in Tableau, which means Tableau gonna process it first. And the Tableau calculation filter is the least important and has the lowest prio. So that means Tableau gonna process it as the last one. So the order of the filters in Tableau are very important to understand in order to know where to apply which filter. So the order of filters in Tableau are defined like the following. The first filter to be processed is the extract filter. The next gonna be the data source filter. After that we have the context filter. Then we have the dimension filter. Next we have the measure filter. And the last in our list is the table calculation filter. So the top filter gonna be processed first, and as you are moving down the list, the filter gonna be low prio and will be processed as the last. So here again about the usage, the extract filter, data source filter, and the context filter is used to reduce the size of data, and the other three filters gonna be used by the end users for analysis and better understanding the data. And now the question is, where we can create those filters? The extract filter and the data source filter, we can create them in the data source page, and the other filters we can create them in the worksheet page. Alright guys, so now we have the following task where we have to hide sensitive informations. For example, let's say that the USA data in our dataset is sensitive informations and we have to hide all the customers that comes from USA. And now we're gonna go and build a view from the customers. We're gonna take the location, the country, and then let's say we're gonna take the profit from the orders. Alright, so now as you can see in the worksheet, we can see all the countries including USA. So now we're gonna go and hide this sensitive information. In order to do that, we're gonna go to the data source page, and then here on the corner on the top right, we can see filters and we can add a new filter. So let's go and click on it. Then we will get a new window called Edit Data Source Filters. It's really easy. Here we're gonna go to the ads, click on it, and then we're gonna get a list of all the fields that are available in our data source. So since we have to hide the customers from USA, we need the field country. So let's go and check that. Over here, then click next. And here we got another window to set up the filter for the country. So as you can see, we have all the countries here listed. And now we can go and select the countries that should be included in our datasets. Or we can go over here and click exclude, and we're gonna exclude the USA. So that means we are filtering out all the customers with the country equals to USA. So let's go and click OK. Now we can see over here a quick information. So the filter is based on the country, and the details is saying we are keeping the values France, Germany and Italy. So that's it. Let's click OK. So let's go now and check the data in our worksheets. So we're gonna switch back to our view, and as you can see, we cannot find any information about USA. And this can affect as well all the worksheets that are connected to this data source. So for example, if we go over here and create a new worksheet, and we take the countries, drag and drop it over here, you can see again here as well, we don't have the USA, we have the values France, Germany and Italy. And with that, we have protected this sensitive information. Alright guys, moving on to another use case of the data source is to reduce the size of data inside Tableau. This is very critical. If you have a bad performance in Tableau, then you have to start thinking about how to reduce the size of data inside our visualizations. And the first step to reduce the size of our data, we have to decide which fields we're gonna use in order to filter our data. A very common and usual field is that we can reduce the number of years inside our data source. Let's go and build a view. So I'm just going to go and create a new worksheet. Let's take the order dates to the rows, and let's take the profits to the columns. And then let's make it as a bar diagram and show the results. So as you can see, we have inside our data 5 years of data. So here this field is really good candidate in order to reduce the data, and you have to go and discuss it with your users. So you have to ask, do we really need 5 years of data inside the visualizations? Is it enough to have only like the last 2 years or 3 years? So let's say that after discussions with the users, you said the relevant data for the visualizations is starting from 2020. So anything before is not relevant anymore for the visualizations. We would like to have everything starting from 2020. So in order to do that, we're gonna go and build a data source filter. So let's go back to our data source page. We're gonna go again over here. So let's go to the edit, and then we're gonna go and choose the field that we're gonna build the data source filter on top of it. So go to add, and then we need the order date. So we have it over here. Let's go and select it. Okay. And here, since it is a date, Tableau gonna ask us first in which format you want to build your filter. Since we are discussing about the years, so we are interested in the years. I'm just gonna go with the format years and go next. So now with that, we get a list of all years inside our data source. So either you're gonna go and say, okay, I would like to include everything starting from 2020 and not select the old years, or you're gonna say, you know what, I'm just gonna exclude the last 2 years, anything before 2020. So you're gonna go with the exclude, and with that we are removing the old years. I prefer this one over here, since let's say that we get 2023 data inside our data source, you don't have to each time to go and click on it. So with that, we are saying all the data are relevant starting from 2020. Let's go and hit OK. And with that, you can see inside our data source filters, we got a new filter based on the years of order date. And here you can see some details. It says it keeps 2020, 2021 and 2022. So with that, we are filtering now the data source based off the order dates and the country. Let's go and hit OK. And as you can see here, we have now 2 filters in the data source. Let's go back to our view, sheet 7. And we can see that we have only the data starting from 2020. All old data are not presented anymore inside our visualizations, which is really great way in order to reduce the stress and the size of data that Tableau has to handle. So with that, we are reducing the scope of data, and as well we are gonna get great performance in Tableau. So this is how we use the data source filters in order to reduce the size of our data and as well to hide the sensitive informations. But here don't forget that all the worksheets that are connected to this data source gonna be affected with those filters. Alright, so now we're gonna learn how to build a context filter in Tableau. Let's say that we have the following view. We're gonna have the category from the products and as well the subcategory. And let's take for the measure the profits. So let's take it over here. And as well, let's change the colors. So we're gonna put it over here as well. So now in this view, we have all the categories: furniture, office supplies, and technology. But the users want in this view to focus only on the office supplies. And for this specific view, all the other categories are irrelevant informations. So they want only to focus on the office supplies by profits. So that means we want to filter the data by category. In order to do that, we're gonna go to the category over here, hold Control and put it on the filters. And then we're gonna get again the same window for filtering. And here you can see the 3 values values, furniture, office supplies, and technology. For this view, we want only the office supplies. So what we're gonna do, we're gonna remove the others and leave the office supply, then hit OK. So as you can see now, we removed everything and we have only the one category, the office supplies. The job is done, right? So we have the office supplies by profits and we filter the data. The answer is yes, the task is done, but we are not using the full power of Tableau. Since here the focus is only about the office supplies and we are focusing on this subset of data, we could go and reduce the whole data sets to only this category. And with that, you're gonna win a lot of performance in Tableau because you are focusing only on subsets and all other data is removed from this visualization. So in such a scenario, we can go and use the power of context filters. So now the question is how to make our filter as a context filter. So as you can see now in the filters, we have our category, it is blue pill and it is as well a dimension. So this filter type called dimension filter. In order now to promote it to the context filter, as we learned before, that we have specific order of the filters, we have context, then dimension. All what we have to do is to right click on it, and here we have the option of adding to context. Once you do it, you will see that our filter now has the gray pill. The gray pills indicates that this filter is a context filter. So now you might notice nothing changed over here. We have exactly the same view, but we optimized the background in Tableau where we created a temporal datasets and it has only the category office supplies. So it's really small table compared to the whole data source. Alright, so now I want to show you how Tableau processes the different types of filters. As we learned, the order of the filters are really important. So that means the context filter gonna be processed first, then the dimension filter. So the context filter is dominating the behavior of the dimension filter. Alright, so now we're gonna go and add dimension filter in our visualization. We're gonna use the subcategory in order to do that. So right click on it and click over here, show filter. So as you can see on the right side, we have all those values that are included in the office supplies. But in our original data source, we have way more subcategories as we are seeing now from this view. And this is exactly the effect of the context filter on this dimension filter. So we are seeing only the values inside this context. Alright, so now we're gonna go and change the definition of the context filter and see the effect on the dimension filter. So let's go again to our context filter, right click on it and edit filter. Let's bring it here side by side to our dimension filter. So we have only those values and we have over here on the context filter only the office supplies. If we go now and include as well the technology, let's apply and see that on the right side the value is gonna change. So let's go there. And now as you can see in the dimension filter subcategories on the right side, we have more values than before because we included in our context in our temporal table the technology data. So we can go and change the values around. So let's have only the furniture, check the right side, apply, and you can see we have only 4 subcategories. So with this you can see that the context filter is really dominating all other filters below it. So understanding the order of the filters, you can understand how Tableau works with those different types of filters. So now I'm gonna bring the context filter again to the office supplies and hit OK. And one more thing about the context filter, as we learned before, it is flexible. That means we can reduce the size of data only for one worksheet. So that means if you go to any other worksheets, you will not find here any context filter. So you can go and decide for each worksheet whether you want to reduce the size of data or not. Unlike the data source filter, where it can affect the whole workbook, any worksheet that is connected to this data source. So with the context filter, we have way more flexibility. And now you might ask, can we use the context filter to hide sensitive informations? Well, the answer is no. Let me show you why. Let's have a quick example. Let's take the customers again, and we have the country, city, and let's take as well the profits. So as you can see over here, we don't have the USA data because we have the filtered data source. And now let's say that the data of Germany is now sensitive and we want to protect it using the context filter. So let's go and do that. So we're going to take the countries, hold Control and put it on the filters. And we're going to say we want to exclude Germany. So I'm going to click over here on the exclude and then hit OK. As you can see now in the view, we don't have any informations about Germany, and we go and promote the country to context filter. So right click on it and add to context. And now you might say, okay, everything is fine. We don't have any informations about Germany, so we are secure. Well, not really. There is still a way in order to see the German data in the view. Let me show you how. If you go to the city over here and let's show it as a filter, on the right side, you will find all the cities from France and Italy. So there is no cities from Germany or USA. But here we have an option on the filters. So if you go to this small arrow over here, then we can go over here and say all the values from the database. I'm gonna explain all those options later, don't worry about it, but let's go and click over here. So now as you can see, the filter is showing data about Germany. We have Berlin, we have Stuttgart. So that means the data are not really protected. So that means we are hiding the sensitive data from the view, but still we can see all the values from the filter. That's why never use context filter to protect your sensitive data or confidential data. Because even if we are seeing the data only in the filters, it's still exposing the data and the data is not protected. So that means if you want to protect your data and hide the sensitive informations, use only data source filters. Alright, so now we're gonna move to the next filter in our chain. We have the dimension filter. We have already created some dimension filter in our view, but now let's go in details and see all the options that we have. Alright, so now let's go to the filters on these shelves, and you can see that we have the subcategory. It is a discrete dimension. That's why we have the color of blue. And now in order to see all the options, right click on it and edit filter. And now you already know this window. Let's just bring it over here to see the effect directly in the view. So first we have here different tabs. The first one is going to be about the manual selection, and the rest is going to be a dynamic filter. So here we have 4 tabs: general, wildcards, condition, and top. So the first one is going to be the manual selection of the values, and the rest is going to be like you are defining a rule, and the filter is going to be dynamic. So here as usual, since it's discrete, we're going to see the list of all possible values that we can see, and then you can go and manually select or deselect values from this list. And as you can see on the right side, we have exclude. The default in Tableau is include. So that means anything that I'm selecting from this list, it's going to be included in the view, and anything that I'm not selecting, it's going to be excluded from the view. In order to have the opposite effects, what we can do, we can click on exclude, and now we're going to have all the values that are selected are crossed out. So that means they are excluded from the view, and everything that is not selected going to be included in the view. So here it really depends. If you want to exclude only 2 values from a long list, then it makes sense to go and use exclude. So now if you go and select apply, you can see in the view the remaining values are application, art, and binders. So Tableau did exclude all those values. And you're gonna have the same effect if you deselect the exclude and select only the application, art, and binders. And in order to remove our selections, we can remove everything from here, so select none, and we can reapply our selection on the application, art, and binders. And as you can see, we're gonna have the same effect. So this is how you work with the manual selection at the first tab, general. But now let's move to the next one, and before that I want to include everything over here so we don't affect the next one. So let's apply, and then we go to the wildcard. So here we're gonna work with the wildcard. If you have a dimension with high cardinality, that means you have a long list of all possible values in the dimension, and if you go and select manually everything, it's gonna be really painful. So instead of that, we can go and define the rule if there is a rule to define. So here we have like an input field. We can write something like, for example, A. So here we have 4 options. The first one is contains. It gonna means that somewhere in the word there is a character A. And then the second option we have start with. It's gonna mean that the word gonna start with the character A. The next one is exactly the opposite. It's gonna end with A. Then the next one we have exactly matches. That means the word should contain only the value A. So let's start with the first one. If the word contains A somewhere, then it's gonna stay in the visualization. Now as you can see, all the words contains A somewhere. So the application, we have it here at the start and at the middle, art as well at the start, and here we have it in the middle, and so on. Let's try out the second one. It's gonna say if the word starts with A, it's gonna stay in the view. So let's hit apply. So as you can see, we have only 2 words that starts with A. Alright, so now let's go to the next option. We're gonna have ends with, but instead of A, we're gonna have S. So any words ends with S gonna stay in the view. So let's apply that. And as you can see, all those words ends with the character S. Well, now you might ask, is it a case sensitive? Well, it's not. So if you have a big S, as you can see, it's still Tableau gonna select those values. And now let's go to the last one. It's gonna be exact match. So if you go over here and select OK, you will not see any data, but if you have exactly labels and hit apply, you will get only one subcategory. It is the labels, but we don't use it usually. We use contains or start with, ends with. So this is how the wildcard works. Let's clear everything in order to have the data. So we have it contains and hit apply. Now let's move to the next tab. We have a condition. In the previous tutorials with the parameters, we have already worked with the conditions and top. So here what we're gonna do, we're gonna define the rule, and Tableau gonna go and check all the values and filter out all the values that are not meeting this condition. So for example, if you are checking our view, we have some minus values in the profits and we don't want to see it. So we will go and define a rule that we want to see all the profits that are higher than 0. So only the positive profits. In order to do that, we're gonna select over here by field. Tableau gonna show you immediately the measure that is using in the view. So we are using the profit, sum is correct, So we're gonna go over here and say the sum of the profit should be higher than 0. So with that, you have defined the rule, and let's hit apply. So as you can see, we have just removed the subcategory that does not fulfill this condition. So that's it. This is really easy. We're gonna move to the next one, but first let's reset everything. So we're gonna select none, and then we're gonna hit apply. In this tab, we can define if we want to see the top 10 products or 5 products, or the lowest or the bottom 5 products. So here again, we have to define the rule for Tableau, and Tableau gonna filter the data based on our rule. So here we have two options. Either we have the top subcategories or the bottom subcategories. So let's go by field over here. And then here we have two options, as I said, top and bottom. And then we're gonna define, is it top 10, is it top 5, or top parameters as we learned before. And here we're gonna stay with the same since we are using the profit, and that's it. Let's hit apply. And now we can see on the view that Tableau did filter our view based on our rule. So now we have the top 5 subcategories. Alright, so that's it. This is the different options on how to filter the dimensions. I'm gonna deselect everything over here, and then we're gonna go to the manual selection and then hit OK. So instead of predefining the rules for the users, we're gonna offer the whole dimension as a quick filter for the end user. And as you know, in order to do that, we're gonna go to the dimension, right click on it and show filter. So the user is gonna go to the quick filter on the right side and start selecting the values that suits their needs. Alright guys, so now let's move to the next one. We have the measure filter. As we learned in the order chain, it is below the dimension filter. So let's see how we can create a measure filter. Alright, so in order to create a measure filter, we're gonna go to the sum of profits. Let's hold Control, drag and drop it to the filters. Then we're gonna get a new window in order to configure our filter. And since it is continuous measure, Tableau gonna ask us, do you want to filter the original data, all values, or do you want to do the aggregations and then do the filters? So since it's measure, we have the following aggregations like sum, average, median, and so on. Or if you want to do only the filter on the original data, then you're gonna go and select all values. But since we have sum of profit, I would like to go with the sum aggregation. So let's select that and then go with next. And now we're gonna get a new window in order to configure our measure. And here we have 4 options: range of values, at least, at most, and special. Since our measure is continuous, Tableau gonna present it as a range. It has a start and end. So it's not like the dimensions where we're gonna get a list of all values from the data source. We will get only aggregated data, and we can configure only start and end. So in the first option, we can configure the starting point of the range and as well the end point of the range. So you can control both of them. In the next one, we can control only one of them, only the starting point. So at least here we can specify what is the minimum value that is allowed in the visualizations. And the next one is going to be exactly the opposite. At most, we can define the end point of the range. What is the highest value that is allowed in the visualizations? So again, the range of values, we can specify the start and the end. At least we can specify only the starting point, and at most we can specify only the end point of our range. Then the last one, the special, is about the null values. So here we have 3 options. Null values, if only you want to see the null values from this filter. Null values, that means you don't want to see any nulls inside our data, or all values, you are allowing both of them. So as a default, we stay with all values. I'm gonna stick with that, and I would like to configure both of the end and the start of our continuous measure. So that's it. As you can see, it's really easy. Let's go and hit OK, and with that you can see we got a new filters inside our filters, and it has of course the green color. Alright, so first we're gonna go to our measure filter and show it as a quick filter. So right click on it and show filter, and now we can see the range on the right side. Let's just make it a little bit bigger to see the range. So now as you can see, we have like start and end, but it is not completely for the whole bar. Here Tableau want to show you that we are not showing all the values, we are showing only the range of the subset. So now what can happen if we take the end to the right and the end to the left? Nothing gonna happen on the view, we're gonna have exactly the same data, but here we can see in our range there is different colors. The light part gonna indicate that if you change the values here, nothing gonna happen in the view. So as you can see, if I just move it over here, the view will not be filtered. And now if I start moving the start inside the dark parts, you can see that now we have now an effect on the view. So the dark color in the slider is the relevant values, and the light part is the unrelevant values. Alright, Alright guys, so now we're going to talk about the last type of filters in Tableau, the table calculation filter. It is the bottom of the chain, and you can see each type of filter is going to have an effect on this type. Alright, so now let's learn how to build table calculation filter, and as the name suggests, it is a calculation, and we're going to have a whole section on how to create calculations in Tableau. So now don't worry about the details how to create calculations in Tableau, just follow me with the steps now. Alright, so now we're going to go to our measure in the marks, right click on it, and then here we have the option of quick table calculations, and then we're going to have a list of all different calculations that you can do it on the table. And now we will go with the percent of total, so let's select that, and now we can see a small icon to the measure. It indicates that this is a table calculation, so hold Control, drag and drop it on the filters and release. So here, since it's a continuous field, we have to define it as a range, so let's click OK. And now we can see in the filters two measures for the same field. The first one without triangle icon, it means it is a measure filter, and the second one with the triangle icon, it means it is table calculation filter. So what we can do with that, we can offer it to the users. So we're gonna right click on it and show filter. We can see it now as a quick filter on the right side, and the user can go and use the filter. So that's all about the table calculations filter. Alright, so with this we have learned the different types of filters in Tableau and how the order of the filter in the chain gonna affect each others. Alright, so now let's have a quick summary. We're gonna start with the extract filter at the top. We can use it only on the extract connections, and we cannot find it in the Tableau public version. Don't worry about it, it is very similar to the data source filter. And then next we're gonna have the data source filter. In order to create it, we go to the data source page, and here in our example we created two data source filters. The first one is to hide the sensitive informations of the country USA, and the second one to reduce the overall size of our datasets. And don't forget that the data source filter gonna affect the whole workbook, all worksheets that are connected to this data source. Then the next filters, we can create them all in the worksheet page, so let's go over there. So here you can see very nicely how the different types of filters are sorted in the filter shelves. The first one, we have the context filter, the gray pill. Context filter gonna create a subset of data or a temporal table only for this view. So it is something locally only for this view. But don't forget, do not use context filter in order to hide or protect sensitive informations, since there is possibility to show the values in the filters. The next three filters, we usually offer it to the end users in order to slice and dice the visualizations, so the users could use it to specify a subset of data to make focus analyses. So next we have the dimension filter, like the subcategory. After that we have the measure filter, and the last one in the chain, we have the table calculation filter. And since those different types of filters has a logical order, it would be nice as well to have this order on the quick filters on the right side. So it makes sense to have the dimension filter at the top, then we're gonna take the measure filter as the next, and the last one gonna be the table calculation filter. Alright, so that's all. It could be confusing at the start, but now after you understand how Tableau works and the logical order of the filters, everything then gonna make sense in the visualization. Alright, so now we're going to talk about how to apply the same filters in different worksheets, because if you are building like different views, you end up having exactly the same filters in each view, and it's going to be time consuming if you are going in each worksheet and adding exactly the same filters. So instead of that, we can share the same filters to be applied in different worksheets, and in Tableau we have 4 different options in order to do that, and we can find those options in the filters. So it doesn't matter which one you're going to pick. Let's go with the context filter, for example. Right click on it, and here we have the option of apply to worksheets, and here you can see the 4 options. As a default, Tableau gonna leave it as only this worksheet. This means locally only for this view. And here we can see other options like all using related data sources, all using this data source, and selected worksheets. Before we try those options, first let's understand those 4 options. Alright, so now we're gonna have a very simple example in order to understand how to apply filters. So we have 2 data sources, DS1 and DS2, and we have different worksheets that are connected to those data sources. So we have the sheet 1 connected only to the data source 1, and the sheet 2 connected to both DS1 and DS2 using data blending, and the sheet 3 only connected to DS2. And now let's say that we are at the sheet 1, and there we created a filter. So now let's learn how to apply this filter in different worksheets using those methods. Alright, the first option, we have only these worksheets. That means this filter gonna be only locally available for the sheet 1. We will not find it in the sheet 2 or in the sheet 3. And this option is as well a default in Tableau. So each time you are creating a new filter in Tableau, it's going to be using this option. Only this worksheet going to be only available in the worksheet where we have created. The next option we have in Tableau, all using this data source. So for example, the sheet 1 is using the DS1. That means the filter going to be applied in all worksheets that are connected to the data source 1. So in this example, we have the sheet 1 because it's connected to DS1, and as well the sheet 2, which is connected as well to the data source 1. But the sheet 3 is not connected to the data source 1, it's only connected to the 2. So that means this filter will not be found in the sheet 3. So that means we are sharing now the filter in all worksheets that are using the same data source. Let's move to the next one. We have all using related data sources. If you are going to use this option, you're going to find your filter almost in all worksheets in your workbook. So we're going to find this filter in the sheet 1, we're going to find it in the sheet 2, and as well in the sheet 3. So that means if you are using this option, we are automatically spreading our filter in almost all worksheets. Let's go to the last one, and it is interesting one, selected worksheets. This means we can go and manually selecting which worksheets can include my filter. So for example, I could say I want to see my filter in the sheet 1 and as well in the sheet 3 without any rule. So as you can see, we have here more control where our filter can be applied. In the last two, all using this data source or all using related data source, there is like a rule, and Tableau gonna go and automatically spread our filters in the worksheets. In my project, I tend to use selected worksheets more often than the other ones because I would like to have control where my filters should be appear in which worksheets. So that's all about the concept of those 4 options. Now let's go back to Tableau and try those options. Alright guys, so back to our filters, we're gonna go to the category, we're gonna stay with the context filter, right click on it and go to the apply to the worksheets, and you can see the selected option here is only these worksheets. This one is the default. So with that, it means this context filter gonna be found only in these reports. If we go to the other reports, we will not find it. So in order to change that, we're gonna go again to the context filter, right click on it, and let's try now all using this data source. So let's click on it. And now if you take a look to our filter, we can find a small icon that indicates this filter is used in different worksheets that are using the same data source. In this view, we are using the big data source. As you can see, we have it as primary data source. So any worksheets, any view is using this data source, this filter can be applied on it. So let's go to the different views over here. So we're going to switch to this one. You can see we have the context filter and as well the first one, since both of them are using the big data source, and the filter going to be applied automatically on it. But now let's create a new view where we are using different data source. So let's switch to the small data source and let's take anything. So let's take the first name, and as you can see, the filter going to stay empty because the big data source is not used in this view. But now let's go and use the big data source and see what Tableau gonna do. So let's remove the first name, switch back to the big data source and take as well anything. Let's take the last name. As I'm dropping in this view, this data, you can see Tableau automatically gonna bring me the context filter because it must be used in all worksheets that is using the big data source, which is really useful if we have different worksheets using the same, for example, context filter. So instead of creating the same filter over and over again, we can create it in one worksheet and then spread it to all sheets that are using the same data source. Okay, so that's all for this option. Let's go back to our context filter and try something else. Let's switch the apply to all using related data sources. Let's try this one. So click on that. And now you can see that we got a new icon from Tableau, indicates that this filter going to be applied to all worksheets with the related data source. So now let's go and check what can happen to the other sheets using this option. We're gonna find now this filter almost everywhere. So in the first sheets, you can see we are using the same data source. So it's gonna be like this. We have the context filter applied to the view. In the second sheet, we're gonna see again the same context because we are using the same data source. Let's go now and create a new sheet where we're gonna use the small data source. So we are using different data source. So click on that and let's take, for example, the first name to the view. So now as we can see in the filters, we have our context filter, even though that we are using different data source. We are not using the big data source, but Tableau brings this filter here because we are using this option. But as you can see, it's red. So what is going on over here in the filter? If you mouse over it, it says data sources that contain logical tables cannot be used as a secondary data source for data blending. Since this filters comes from other data source, from the big data source, Tableau has to make a data blending between them in order to connect it. And it will not work if you have in the secondary data source a logical data model. As you know, in our big data source, if you switch to this page over here, we have a data model, we have a logical model where we connected the customers with the orders and so on. Tableau don't like it as a secondary data source to has a data model, so it will not work. But if you have only one table, or if you have like multiple joins at the physical layer, this is gonna be working. So if you go back again, it's gonna stay red as long as the secondary data source has a logical data model. But if you have one table, everything gonna be fine, you will not get this error. Alright, so with this option, as you can see, whether you are using the same data source or different data source, our filter gonna appear. So now let's go and check the last option. So let's go back to our view over here, go to the context filter, right click on it, apply to worksheets, and now we're gonna go to the selected worksheets. So let's click on that. Alright, so now we have a very simple table where we have a list of all worksheets and as well descriptions about the data sources and some details. So now we can go and manually select which worksheets can include our filter. So as you can see, we have like everything is selected because we use the option of related data sources. I don't want that, so I'm going to deselect everything and start from the scratch. So I would like my filter to be the first one, the second one, and this one is like grayed out because we are currently in this worksheet. So it's anyway selected, and the other ones I'm gonna leave it deselected. So that's all. Let's go and select OK. So now if you check the filter again, we can find a new icon that indicates this filter now is used in different worksheets that we manually selected. So let's visit the first report. We can find our context filter, the second one the same, the third one anyway, because we have here created this context filter. But now if you go to the different worksheets, you will not find this context filter. And as I said earlier, I use this option a lot in my projects to have control in which worksheets I want to see my filters. So generally speaking, those options are a really great way to share your filters in different worksheets and solve the problem of creating the same filters over and over again. Alright guys, so now we're going to talk about how to customize our quick filters. But first, let's understand what are quick filters. Any filter that you are presenting in the view, in the visualizations, for the end user to interact with the view, considered to be a quick filters. For example, all those filters on the right sides in the view are quick filters. We have the subcategory, the sum of the profits, those stuff are quick filters. And the users can go and start selecting the values inside those quick filters to interact with the visualizations. So now in order to customize those quick filters, we're gonna go over here in this small arrow and click on it. And here we will get a long list of many options on how to customize our quick filter, and they are as well split into groups. The first group is about how to customize the quick filter. The next set of options is about the filter modes. Then we have here many options about which values can be presented in the quick filter. So we have only relevant values, all values in context, all values in database. So now we're gonna go and focus on these groups of options, but first we have to understand the concepts behind them. Alright, so as we learned before, we have a data source and a worksheet. Inside the worksheet, we have a context filter and visualizations. The data gonna be sent from the data source to the context filter, and then the visualization gonna be querying the context data, and the result gonna be sent back to the visualization. Now inside the view, we can create a filter. Now the question is, which data gonna be presented inside this filter? And here we have many options. The first one is we're gonna get the values from the database, all values in database. So with that, the value is gonna be queried directly from the data source. With that, we are skipping anything inside the worksheet. So we are skipping the data in the context filter and as well in the visualizations. So it doesn't matter what we are doing in the worksheets, the value is gonna come directly from the data source. Alright, so this is for the first option. When we say database, it means the data source informations. The next option we have all values in the context. So this time the values in the filter are gonna come directly from the context filter. As we learned before, the context filter gonna generate a temporal view or temporal data inside the worksheets. So here the value is gonna come directly from the context filter, and anything that's gonna be done inside the view will be not considered in the values in the filter. So with that, we are skipping the visualizations level. We are getting the data directly from the context filter and not from the data source. Alright, so that's all for this option. The next one gonna be only relevant values. So the values for the filter now gonna come directly from the view, from the visualizations. That means any interaction that we are doing in the view, any filtering, gonna affect directly the values that are presented in our filter. So as you can see, those options are really helpful, and Tableau gives us now the control in which data can be presented in our quick filters. Because as you can see in Tableau, we have different layers and different stages, and the subsets and the size of the data can be different from one to another. So normally the size of the data in the data source is way bigger than the context filter. With that, you are defining and you are controlling which data can be presented in my filter. Alright, so now back to our view. Now in order to practice those options, what I'm gonna do, we're gonna bring new quick filters to our view. So let's take the country, right click on it, show filter, and we're gonna get as well the city. Let's go over there, and we can change the order over here. So we're gonna bring first the country, then the city and the subcategory. I'm gonna remove those measures from the filters, so let's just remove them. And with that, we have those filters. So now we're gonna go and check which options do we have inside the quick filter city. So go to the arrow, and as you can see, the current value is all values in the hierarchy, and that's because the city is part of the location hierarchy. But now we're gonna go and change it to only relevant values. So let's go and do that. And now if you take a look to the values inside the cities, we can find almost all the values from the data source. So nothing changed yet. But as we start now interacting with our views, the values in the city start reacting to our selections. For example, let's go to the country over here and start removing some countries. So we're gonna deselect France, Germany, USA. As you can see, the values inside the city is reacting to our selections. So it's like those two quick filters are connected to each other. And this is exactly what the option of only relevant values gonna does to our quick filter. And this is exactly the purpose of this option, only relevant values. Anything that we are doing in the view, the values inside this quick filter can be refreshed and updated with the current selection. And now, of course, if we go and deselect Italy, what's gonna happen? The filter city gonna be completely empty like our view. So it is reacting to our interaction. Now we're gonna go and change it to another option. So let's go over here on the arrow, and now we're gonna change it exactly to the opposite. Show all values in the database. So let's click that, and now what's gonna happen, Tableau gonna go to the data source and bring all the informations about the city and put it on the filter, regardless what we have selected in the view or whether we have a context filter and so on. So now we have a list of all values in the city that is available in our data source, and it will not be refreshed or updated if we are clicking around or interacting with our view. So for example, if I'm adding any other cities or I'm changing any other filters, for example, I'm removing all the subcategories, you can see it's static. Nothing gonna be changed in the city because it's go to the data source, get all the data from there, and that's it. So this is really nice in order to optimize the performance in Tableau and reduce the resources that are used in those quick filters. So now let's go and check something else. We're gonna go and select the all values in the context. So let's click on that. So that means the values inside the cities is responding only to the context filter. Since our context filter is based on the category, we have to bring it to the view in order to change the values. So let's go to the category, right click on it and show filter. So now we have our context filter on the right side. All other filters are dimensional filters. So now the values from the city gonna interact only with the category, not with the country and the subcategory. So now let's try that. For example, if I go to the country, I remove all the values, you can see the values in the view did disappear because we are not selecting any data, but the values in the city still are there. So let's go and select everything. The same for the subcategory. If I remove everything from the subcategory, you see the city is not reacting. So it's still static because it comes from the context filter. So now let's bring everything back. But now if I go to the category, to our context filter, and let's remove office supplies. Once I remove it, you can see now the city is reacting to our view. So we don't have any values because we are not selecting anything from the category. So here you can see there is like connection only to the context filter, but not to the other filter. And this is exactly what's gonna happen if you make the city depending to the context filter. Alright, so with that we have learned the three main options in order to control which value is gonna be presented in our quick filters. But as we started with the city, we saw that there is another option called all values in the hierarchy. It was the default one. So let's go and select that. Once we do it, what we are doing now, we are connecting the dimensions that are in the same hierarchy. If you check our data pane, we have hierarchy that we created previously. It is the location hierarchy, and inside it we have 4 dimensions. So we have the continent, country, city, postal codes. Now all those 4 dimensions, if we use it as quick filter, they're going to be connected to each other's. So let's check the example. Now we have the city and the country in the same hierarchy, and they are connected to each other. And in the category, it's our context filter, it's empty, but still the city is showing values. So that means the city now is disconnected from the context filter or from any other filter that is not in the same hierarchy. So if I go and select here any values in the category, you see nothing is changing in the city, even if I remove everything. But the city gonna react once and start deselecting or selecting values from the same hierarchy. So if I remove France, Germany, USA, you can see now we have only the cities from Italy. So they are like connected to each other's. But here we have something special about the hierarchies, since as we learned, we have dimensions levels, so the country is higher level than the city. So the lower level dimensions will not affect the higher level dimensions. Only a higher level dimension can affect the lower one. So what I mean with that, let's go to the country, select all the values. So as you can see now, we have here in the cities all the values, but if I start deselecting any values from here, you can see the country is not reacting for it because it's higher dimension. Even if I go and deselect everything, I still have the 4 countries. So that means since the city is lower level than the country, it will not affect the country. But if we bring now a higher level than the country, which is the continent, let's see what's gonna happen. So we're gonna go to the continent, right click on it and show filter. I'm just gonna bring it over here. And now as I'm start deselecting stuff in the continent, as you can see, the values in the country are affected with my selection because of the hierarchy. The content is higher level than the country. So with that, as you can see, this is what's gonna happen if we have all values in the hierarchy. You have to pay attention to the levels of the dimensions, and those dimensions are gonna be connected to each other's. So with that, we have covered all those options that we could use in order to control the values inside our quick filters. Okay, so now we're going to talk about a different group of options that we could use in order to customize our quick filters. We have the filter modes. So we have single value list, single value dropdown, slider, custom list, and so on. In order to learn that, we're going to have the following example. So what we're going to do, we're going to go and clean up our filters. I'm going to remove the country, the city, and the continent. And we're going to have the subcategory and category. And we're going to bring as well the product name as a filter. So right click on it and let's go with show filter. And now we have the quick filters on the right side. We have the product name. I'm just going to bring it over here so it looks like our hierarchy. So it starts with the category, subcategory, and product name. Let's show all the values over here. And for the product name, I'm going to change the modes to a drop down or a list. Alright, so now let's start with the first quick filter, the category, and try those modes. We're going to go to the arrow, and as you can see as a default, it is multiple values list. So as you can see, we have the list again here as a single value. So we have the same option, once as single value and other is as multiple value. The same goes for drop down. We have drop down single value and drop down as multiple values. So let's try those stuff out. So we're going to go to the single value list. And as you can see now, the visual of the filter did change to radio buttons. And now as I'm selecting those values inside the category, as you can see, we can select only one value. As the name says, it's only single value list. So that means we are making some kind of restrictions. Only one value is allowed. But if you want to have multiple values as a list, we're going to go and change it back to multiple values list. And here, of course, you can choose different values and different categories without any restrictions. So this is about the modos list, single value, or a drop-down list. Okay, so now let's go and try another mode. So we're going to take this time single value drop-down. So let's switch to this one, And as you can see, with the drop-down, you will not find all the values immediately in the view. You have to click on the drop-down menu over here, and then you can select the values. Since it's single value, again, here we can select only one value. We cannot select multiple values. So I can select one category at a time. And as you can see, it is working. Let's switch now to multiple values drop-down. We're gonna have again here the same thing. We have a drop-down menu, but inside the menu, we can select multiple values. So that's it for the drop down. Alright, so now let's move to another filter mode. We have the single value slider. So let's select that, and with that you can have a slider. We can move it to left and right to have different values, but it is not really interesting for a dimension with string values. We can use it for numeric or dates. Because this is not really nice to have a slider for values, it's better to use the drop down or a list for string values. So that's it for the sliders. I rarely use it in the projects. So now let's move on to another one. We have the custom list, but I will not use it in the category. Let's go for the product name and use a custom list. So click on that. And now as you can see, now the product name don't have any values. We cannot see anything. We have only a search box. So now we can search for a value. Like for example, let's search for Apple and then hit enter. You can see now a list of all products that contains the name Apple. So it's like searching inside this field. So if you can go over here and start selecting the values that you want to be in the filter. So as I'm clicking over here on those boxes, I'm gonna see a list of all values that I'm selecting. So with that, we have created our list using the search box. But here we are not seeing any data because of the category. So I'm just gonna switch it back from the slider to multiple values list. I'm going to select everything, and now we can see that we are selecting only the subcategory phones because we selected over here the Apple. So with this type of list, the customers can go and select their own list. So we can go and add more stuff like Samsung over here. So let's search. I'm going to add those products as well to the list, and with that we are appending or adding more products to the list. If you want to clear everything, we can go over here and clear the list. So this is a really nice way to search for specific value, especially if you have a lot of values inside the product name. And now let's go and try the last option that we have in the filter modes. We have the wildcard. Let's go and select that, and now we can see that we have again a search box where we can enter a value, but now we are searching for specific pattern in our data. In order to show you how this works, we're gonna get the product name as well in our view, and now we're gonna go and search for specific pattern. For example, I want to search for all product that starts with the character A. So in order to do that, we're gonna go over here, enter A. After the A, it doesn't matter which character gonna comes after that. That's why we're gonna use the character star. So let's go with that and then hit enter. So we can see at the product name, Tableau did filter the data depending on our pattern, our search pattern. So we can see over here all the products that starts with the character A. So let's go and have another example. Let's say we want to start with APP, then doesn't matter which character gonna follow up. So we're gonna have the star. Let's hit enter. We have here only 4 products that follow this pattern, and it is the word of Apple. Or we can search for the last characters. So let's say that it should end with S. So instead of having the start at the end, we're gonna have the star at the start. So we have star, then S, then let's hit enter. All those products end with the S character. So if I just like move it over here, some of them are really long names. So you can see, for example, here bookcases, it ends with S, and all those products end with the character S. So this is how this mode works. The wildcard, we can use it in order to search for specific pattern in our data. And again, this is really helpful if we have a dimension with a lot of values. We can use this search box to find the specific data that we need. So with that, we have covered all different modes that we have in this category in order to customize our quick filters. Alright, so now let's move to another set of options to customize our quick filters. In each quick filters, we have a lot of informations. For example, we have this extra button called All, or we have a title, or we can search for specific value, or we can reset stuff and so on. So we can customize all those informations in Tableau. Let's go over here again, and then we can go to the Customize, and now we can see all those options. So show all values, this is exactly the first value that we can select. So if you deactivate it, we're gonna have only the values from the dimension from the filter. But sometimes it's really nice, for example, here in the subcategory, if you are like you want to deselect a lot of values. So you just can go and deselect the all. With that, you are removing all the selections and then you select specific stuff. So with that, we can select the values really fast. Let's move to the next one. We have this small search icon. So if you go over here,
you can search, for example, for art, hit enter, then you're gonna get the value inside this dimension. And if you want to hide it and not show it for the users for some reason, you can go over here on the customize and then deactivate it. So once you deactivate it, you can see the small icon disappeared. But I think it doesn't harm to have it in each quick filter. So let's activate it again. So as you can see, with those options, we are customizing our quick filter. Let's check another option. Let's go to customize. And here it's really interesting to have the show apply button. So let's select that. And once you do it, you're gonna get two new buttons, cancel and apply. So as I'm selecting now in my filter, as you can see, nothing is changing in the view. So that means it will not send any query to the data source or the context filter to get the data. So nothing is changing as long as I'm not clicking here on the apply. So once I click on apply, the filter gonna send a query to the Tableau and Tableau gonna answer with data. This is really nice if you are going to select a lot of values. So each time you are selecting a value, Tableau gonna do the calculations. Maybe it makes sense, first let me select everything and then do the calculations. And if you don't activate this option like in the category, each time we are selecting and deselecting from the filter, Tableau has to react to our interaction. So with that, we are generating a lot of calculations in Tableau as we are clicking around. But over here, as we are selecting the values, nothing is changed until we decide to say, okay, I'm done. Now go and do the calculations. This is again really nice way to reduce the unnecessary calculations in Tableau. Alright, so what else we can customize in our quick filters is the title. So we can decide whether you want to show a title or not, or you can edit the title name itself. So if you go over here, you say, okay, instead of subcategory, I'm gonna have like a minus between them and make everything small for some reason. So let's click OK. As you can see now, the title did change, but the dataset's name didn't change. So if you go to the subcategory, the name stays as it is. We just renamed the filter name. Alright, so with that, we have covered now almost everything on how to customize our quick filters in Tableau. Now I'm gonna show you the best practices of Tableau filters that I usually follow in my projects. Let's go. The first tip that I have for you is to utilize those filters. So the extract filter, data source filter, and the context filter. I saw a lot of projects where developers really forget about them or ignore them because they are not really important in the visualizations, but they are very important for optimizing the performance in Tableau. So my advice here is for you to always have a discussion with the end users about promoting one of those filters that you have in the visualizations to be first an extract filter. If it cannot be an extract filter, then the data source filter, and the last option to optimize the performance is to bring it as a context filter, because sometimes in the visualizations you really don't need all the data. You don't need, like, for example, 10 years of data in the visualizations. So try to discuss it with the users to say, maybe let's bring only 2 years of data to the visualizations, and then you can utilize an extract filter or data source filter in your workbook, which can has a great impact on the performance overall in Tableau. So don't forget or ignore those 3 filters. The second filter tip that I have for you is about optimizing the performance in Tableau, which is avoid using only relevant values in your quick filters. So for example, if we go to the subcategory over here, we can see that it is currently set to only relevant values. If you use this option for all your quick filters, what can happen? The performance in Tableau gonna be really bad and everything gonna be really slow. So we can go and switch it to something else, like all values in database or in context. So we can go and switch that, and with that you're gonna reduce the stress on the memory and the resources in Tableau. But let's understand why. Alright, so now let's understand what can happen in Tableau if you're using in your filters all values in database or in context. It's the same. So once the viewers or the users start their reports, if you're gonna send only one query to the data source, and the data source is gonna answer with the results back. So that means we're gonna have only one initial query as the user starts the view. But in the other hand, if you are using only relevant values, what can happen? The view gonna keep sending queries after query to the data source, always to get an update and refresh in the view. So that means the view gonna keep sending multiple queries for each user interactions, which can really impact the performance in Tableau.
Because each time the user is clicking something or interacting with the view gonna keep sending queries to the data source to get an update about the interaction, which gonna use a lot of resources and memory in Tableau and gonna slow everything down. Because each time the user is clicking something in the view or interacting, the view gonna keep sending queries to the data source, which gonna consumes a lot of memory and resources from Tableau, and it's gonna slow everything down. So be careful with your quick filters. If you're having everything on only relevant values, things might be slow. So if the users are suffering from bad performance in Tableau, maybe think about switching all those filters to all values in context or in the database. I have another filter tip about optimizing the performance in Tableau, which is avoid using dimensions with high cardinality as quick filters. Those dimensions might impact the performance in Tableau. But first, let's understand what is cardinality. So cardinality is the number of distinct values in a field. For example, in our database, we have the customer ID. We have around 800 customers ID, and we have a lot of products names. So those two fields considered to be high cardinality dimensions. In the other hand, we have another dimensions. For example, the category, we have only 3 values, or the countries, in our database we have only 4 countries, and the subcategory as well, we have only 17 subcategories. Those dimensions considered to be a low cardinality, and if you are using them, the performance is going to be okay. But if you are start using those dimensions with high cardinality, the performance might be bad. So the best practice here is to avoid using high cardinality. Alright, so back to our quick filters in our view. As you can see, the category and the subcategory, there are dimensions with low cardinality. So it's fine to leave it at the view, but the product name, it has a lot of values. It is dimensions with high cardinality, and it's really worth to discuss it with the users whether they really need such a filter in the view. And if you find out no one needs it, just remove it from the view just to have a good performance at Tableau. Now let's move to the next filter tip. Is that, let's say that the users really want to see the product name or the customer ID, any dimension with high cardinality in the view. So here the tip is to change the filter modes. So instead of having a drop-down list or a list, we can use a wild match for dimensions with high cardinality. So why having a list of all the products or the customers in the view is a bad thing in Tableau or bad for the performance? Well, each time Tableau has to go to the data source or to the database and prepare a distinct list of all the customers or all the products to be presented in the view. So instead of having a list, we could go and change it to wildcard match, and as you can see, Tableau is not preparing anything, so we don't have any values to be presented in the view. Only if the customers start interacting with the quick filter, then after that Tableau gonna go to the database and brings the relevant values. And with that, we are avoiding using a lot of resources and unnecessary calculations in Tableau. So if you have a dimensions with high cardinality, either avoid using it, or if you want to use it, just use the wildcard match. Alright, so let's move to the next best practice in Tableau. Is as well about optimizing the performance in Tableau, which is start using the apply button in your quick filters. Because if you don't use it, let me show you what's gonna happen. Each time I'm deselecting something, it is like a query sent to the data source. So this is one query, second query, third query, fourth query, and so on. So each time I'm clicking on my filters, there will be generated a lot of queries to the data source, which is consuming a lot of performance. So instead of having such a filter, we can customize and add the apply button. So as we learned before, we can go over here, then customize and show apply button. So now as I'm clicking on those values in the filter, no query is generated to the data source. So we are not using any resources in Tableau. And once I'm done selecting what I need, then I'm gonna hit OK or apply. What's gonna happen? One query gonna send to the data source to bring the result to the view. So with that, we are reducing the number of queries that our visualizations is generating in Tableau, which is really great for the performance. So my recommendation here, if you have a filter like the subcategory or a dimension with high cardinality where you are using a list, use apply button, because the users will not select only one value, they usually select multiple values, and then at the end they can apply. But a filter like the category, we have only 3 values, like it doesn't worth to use apply button, it's only 3, so the user is gonna maximum like generate 3 queries. So it's fine to not use apply button with the dimensions with really low cardinality. So with the high cardinality or medium cardinality like the subcategory, go and use apply button. Alright, the next filter tip that we have is as well about the performance in Tableau, which is avoid using exclude and always use include if it is possible. So for example, if we go to the subcategory, we have here the option of using include or exclude. So if you are using exclude values, those queries that are going to be generated in Tableau are more complex than include. More complex means more resources and might slow down the report or the view in Tableau. So avoid using exclude when it's possible. So I'm going to switch it back to include, which has better performance. Alright, so let's move to the next one, and I promise you this is the last one about the performance, which is minimize the number of quick filters in your view. Those quick filters gonna take not only the space in the view, but also gonna generate a lot of queries, a lot of stress, gonna bring the whole performance in Tableau down. So try to avoid using a lot of quick filters and discuss with your users each time they need new filters, whether it's really necessary to put it in the view. Because I saw a lot of projects that the users always want a lot of filters. So try to discuss them and not always bringing a new quick filter to the Tableau, because you're gonna end up having really bad performance in the view and no one's gonna be happy having bad response time in the visualizations. So try to minimize the number of quick filters in Tableau so that everyone is happy. So now let's bring more filters to our view. We're gonna go, for example, and pick the order date. I'm gonna show it as a filter. Let's take the location informations, the country, and as well maybe the city. And now we have to start sorting those informations. I usually start in my projects with the first filter is the date or the time aspect that we have in the visualization. And here we have only the order date. So we're gonna drag and drop it on the top, because usually the users gonna start thinking which date, which year I want to see in my visualizations. So they're gonna focus always first on the time and the date aspect. And after that, we have two kinds of informations or two hierarchies in the quick filters. So we have here the location informations, we have the city and the country, and then here below we have the informations about the product, and as well they are hierarchy. So here we have to not mix them together. So separate them. First start with the topic, for example, the location. So first we're going to talk about the city and the country, and then we're going to talk about the product informations. And here follow as well the logical order in our hierarchy. So our hierarchy starts, for example, with the country as a higher level than the city. So start always with the higher level, then move down to the lower level. So for example, here we should bring the country on top, and then the city should be below it. And if we take, for example, the postal code, let's have it as well in the filter, the postal code should be below the city. So as you can see in the quick filter, we are rebuilding the logical order of the levels in the hierarchy. The same goes for the product. So we have first the category, the subcategory, then the product name. Here everything is fine. So with this, as the users start filtering the data, they start from top to down. So there is like logical order of the fields, which really makes sense. Alright, so let's move to the next filter tip that we have. To not use all values in dimensions with very low cardinality. So what I mean with that, for example, let's check the country. The country has only 4 values, and really it makes no sense to use all, because it's only 3 values or 4 values, and the users can go and select those values without now selecting all or deselecting all. So this dimensions is really low cardinality, and we can go and remove this option. So let's go to the customize and remove it. With that, we have like more space to show to the users, and this option usually takes a lot of space. Alright, so let's move to the next one, to the city, and let's check the values. As you can see, we have a lot of values, and here it makes sense to leave it as it is. So we're gonna leave the all values, the postal code as well. It's like relative high cardinality, so we're gonna leave it. The category here, we have only 3 values, so it really makes no sense to use the all values. So I'm gonna go and remove it as well from here, and with that we have now more space. We didn't waste space for that. The subcategory here, let's make it bigger a little bit and see. You can see we have a lot of values, and it makes sense to select all subcategories or deselect, so I'm gonna leave it for that. So that means we just changed that for the category and the country, which is really dimensions with very low cardinality. Alright, so now we're gonna move to the final filter tip that I have for you that I usually use in my projects, which is as well about the design and the look and feeling in Tableau. So here we're gonna use the suitable filter modes in the quick filters. So let's see what I mean with that. First, we're gonna start with the order date, or with the date that we have usually in our view. I usually tend to use here like a continuous field instead of a list of distinct values. So what I mean with that, I usually go over here on the year of order date, right click on it and convert it to continuous. So with that, we're gonna have like a range between two values, which can has as well less space in Tableau. So let's go and switch it. So now, as you might already notice, the order date, the quick filter did disappear because we changed the role from discrete to continuous. So let's go and show it again. And as you can see now, we have the quick filter very minimum and not taking a lot of space. So this is really nice as a start to have a range between two values for the date. Let's move to the next one. We have the country. So the country is dimensions with very low cardinality. And here I tend always to use a list with multiple values. So everything here is correct. Let's check that. So it is multiple values, a list. So I'm gonna leave it as it is. The next one, we have the city. Here we have a lot of values, and here we can only see like 3 values from the whole filter. Doesn't make sense to have it as multiple value list. Instead of that, I was gonna say this is dimension with medium cardinality. We're gonna always tend to use a drop down for that. So I always skip this single value. It's like restriction that has no meaning. So we're gonna go with the multiple value drop down. And with that, as you can see, we have a minimum space. We have only like one value that we can see. So if the users want to select the cities, so the user is going to go and select the values that they need and then close it. So it's really minimum and don't take a lot of space. The next one, we have the postal code as well. Here we have the same situation, a dimension with a medium cardinality. We have like a lot of values, so we will not leave it as a list. We're gonna have it as a drop down menu. So as you can see, the size compared to the city is really big in the visualization. So we're gonna go as well over here and change it to multiple values drop down. The next one is the category. It's exactly like the country, only 3 values, very low cardinality. We're gonna leave it as it is. And I think for the subcategory, you already know that it has like medium cardinality. We're gonna go over here and make it a drop down. So now we're gonna move to the last one. We already talked about it. The product name is huge and has a lot of values. The best practices here is to use a wildcard match for this value. And for example, let's take another one. Let's take the first names. So I'm gonna show the filter over here, and we're gonna bring it just down the last one beneath the product name. This as well is a huge filter. It has a lot of values, and here is as well dimension with high cardinality. So we're gonna go and switch the modes to a wildcard match, exactly like the product name. So as you can see, we have now a lot of filters, which is not really good for the performance, but we saved a lot of spaces as we change the filter modes. So with that, we have really nice quick filters on the right side, not taking a lot of spaces. So with that, I covered all the tips and tricks or best practices that I usually use in Tableau projects if I'm using filters. Now I'm gonna show you the best practices of Tableau filters that I usually follow in my projects. Let's go. The first tip that I have for you is to utilize those filters. So the extract filter, data source filter, and the context filter. I saw a lot of projects where developers really forget about them or ignore them because they are not really important in the visualizations, but they are very important for optimizing the performance in Tableau. So my advice here is for you to always have a discussion with the end users about promoting one of those filters that you have in the visualizations to be first an extract filter. If it cannot be an extract filter, then the data source filter, and the last option to optimize the performance is to bring it as a context filter, because sometimes in the visualizations you really don't need all the data. You don't need, like, for example, 10 years of data in the visualizations. So try to discuss it with the users to say, maybe let's bring only 2 years of data to the visualizations, and then you can utilize an extract filter or data source filter in your workbook, which can has a great impact on the performance overall in Tableau. So don't forget or ignore those 3 filters. The second filter tip that I have for you is about optimizing the performance in Tableau, which is avoid using only relevant values in your quick filters. So for example, if we go to the subcategory over here, we can see that it is currently set to only relevant values. If you use this option, for all your quick filters, what can happen? The performance in Tableau gonna be really bad and everything gonna be really slow. So we can go and switch it to something else like all values in database or in context. So we can go and switch that, and with that you're gonna reduce the stress on the memory and the resources in Tableau. But let's understand why. Alright, so now let's understand what's gonna happen in Tableau if you're using in your filters all values in database or in context. It's the same. So once the viewers or the users start the reports, if you're gonna send only one query to the data source, and the data source gonna answer with the results back. So that means we're gonna have only one initial query as the user starts the view. But in the other hand, if you are using only relevant values, what can happen? The view gonna keep sending queries after query to the data source, always to get an update and refresh in the view. So that means the view gonna keep sending multiple queries for each user interactions, which can really impact the performance in Tableau. Because each time the user is clicking something or interacting with the view gonna keep sending queries to the data source to get an update about the interaction, which gonna use a lot of resources and memory in Tableau and gonna slow everything down. Because each time the user is clicking something in the view or interacting, the view gonna keep sending queries to the data source, which gonna consume a lot of memory and resources from Tableau, and it's gonna slow everything down. So be careful with your quick filters. If you're having everything on only relevant values, things might be slow. So if the users are suffering from bad performance in Tableau, maybe think about switching all those filters to all values in context or in the database. I have another filter tip about optimizing the performance in Tableau, which is avoid using dimensions with high cardinality as quick filters. Those dimensions might impact the performance in Tableau. But first, let's understand what is cardinality. So cardinality is the number of distinct values in a field. For example, in our database, we have the customer ID. We have around 800 customer ID, and we have a lot of products names. So those two fields considered to be high cardinality dimensions. In the other hand, we have another dimensions. For example, the category, we have only 3 values, or the countries, in our database we have only 4 countries, and the subcategory as well, we have only 17 subcategories. Those dimensions considered to be low cardinality, and if you are using them, the performance is going to be okay. But if you are start using those dimensions with high cardinality, the performance might be bad. So the best practice here is to avoid using high cardinality. Alright, so back to our quick filters in our view. As you can see, the category and the subcategory, they are dimensions with low cardinality. So it's fine to leave it at the view, but the product name, it has a lot of values. It is dimensions with high cardinality, and it's really worth to discuss it with the users whether they really need such a filter in the view. And if you find out no one needs it, just remove it from the view just to have a good performance at Tableau. Now let's move to the next filter tip. Is that, let's say that the users really want to see the product name or the customer ID, any dimension with high cardinality in the view. So here the tip is to change the filter modes. So instead of having a drop-down list or a list, we can use a wild match for dimensions with high cardinality. So why having a list of all the products or the customers in the view is a bad thing in Tableau or bad for the performance? Well, each time Tableau has to go to the data source or to the database and prepare a distinct list of all the customers or all the products to be presented in the view. So instead of having a list, we could go and change it to wildcard match, and as you can see, Tableau is not preparing anything, so we don't have any values to be presented in the view. Only if the customers start interacting with the quick filter, then after that Tableau gonna go to the database and brings the relevant values. And with that we are avoiding using a lot of resources and unnecessary calculations in Tableau. So if you have a dimensions with high cardinality, either avoid using it, or if you want to use it, just use the wildcard match. Alright, so let's move to the next best practice in Tableau. Is as well about optimizing the performance in Tableau, which is start using the apply button in your quick filters. Because if you don't use it, let me show you what's gonna happen. Each time I'm deselecting something, it is like a query sent to the data source. So this is one query, second query, third query, fourth query, and so on. So each time I'm clicking on my filters, there will be generated a lot of queries to the data source, which is consuming a lot of performance. So instead of having such a filter, we can customize and add the apply button. So as we learned before, we can go over here, then customize and show apply button. So now as I'm clicking on those values in the filter, no query is generated to the data source. So we are not using any resources in Tableau. And once I'm done selecting what I need, then I'm gonna hit OK or apply. What's gonna happen? One query gonna send to the data source to bring the result to the view. So with that, we are reducing the number of queries that our visualizations is generating in Tableau, which is really great for the performance. So my recommendation here, if you have a filter like the subcategory or a dimension with high cardinality where you are using a list, use apply button, because the users will not select only one value, they usually select multiple values and then at the end they can apply. But a filter like the category, we have only 3 values, like it doesn't worth to use apply button, it's only 3, so the user is gonna maximum like generate 3 queries. So it's fine to not use apply button with the dimensions with really low cardinality. So with the high cardinality or medium cardinality like the subcategory, go and use apply button. Alright, the next filter tip that we have is as well about the performance in Tableau, which is avoid using exclude and always use include if it is possible. So for example, if we go to the subcategory, we have here the option of using include or exclude. So if you are using exclude values, those queries that are going to be generated in Tableau are more complex than include. More complex means more resources and might slow down the report or the view in Tableau. So avoid using exclude when it's possible. So I'm gonna switch it back to include, which has better performance. Alright, so let's move to the next one, and I promise you this is the last one about the performance, which is minimize the number of quick filters in your view. Those quick filters gonna take not only the space in the view, but also gonna generate a lot of queries, a lot of stress, gonna bring the whole performance in Tableau down. So try to avoid using a lot of quick filters and discuss with your users each time they need new filters, whether it's really necessary to put it in the view, because I saw a lot of projects that the users always want a lot of filters. So try to discuss them and not always bringing a new quick filter to the Tableau, because you're gonna end up having really bad performance in the view and no one gonna be happy having bad response time in the visualizations. So try to minimize the number of quick filters in Tableau so that everyone is happy. So now let's bring more filters to our view. We're gonna go, for example, and pick the order date. I'm gonna show it as a filter. Let's take the location informations, the country, and as well maybe the city. And now we have to start sorting those informations. I usually start in my projects with the first filter is the date or the time aspect that we have in the visualization. And here we have only the order date. So we're gonna drag and drop it on the top, because usually the users gonna start thinking which date, which year I want to see in my visualizations. So they're gonna focus always first on the time and the date aspect. And after that, we have 2 kinds of informations or 2 hierarchies in the quick filters. So we have here the location informations, we have the city and the country, and then here below we have the informations about the product and as well their hierarchy. So here we have to not mix them together. So separate them. First start with the topic, for example, the location. So first we're going to talk about the city and the country, and then we're going to talk about the product informations. And here follow as well the logical order in our hierarchy. So our hierarchy starts, for example, with the country as a higher level than the city. So start always with the higher level, then move down to the lower level. So for example, here we should bring the country on top and then the city should be below it. And if we take, for example, the postal code, let's have it as well in the filter, the postal code should be below the city. So as you can see in the quick filter, we are rebuilding the logical order of the levels in the hierarchy. The same goes for the product. So we have first the category, the subcategory, then the product name. Here everything is fine. So with this, as the users start filtering the data, they start from top to down. So there is like logical order of the fields, which really makes sense. Alright, so let's move to the next filter tip that we have. to not use all values in dimensions with very low cardinality. So what I mean with that, for example, let's check the country. The country has only 4 values, and really it makes no sense to use all because it's only 3 values or 4 values, and the users can go and select those values without now selecting all or deselecting all. So this dimensions is really low cardinality, and we can go and remove this option. So let's go to the customize and remove it. With that, we have like more space to show to the users, and this option usually takes a lot of space. Alright, so let's move to the next one, to the city, and let's check the values. As you can see, we have a lot of values, and here it makes sense to leave it as it is. So we're gonna leave the all values, the postal code as well. It's like relative high cardinality, so we're gonna leave it. The category here, we have only 3 values, so it really makes no sense to use the all values, so I'm gonna go and remove it as well from here. And with that, we have now more space. We didn't waste space for that. The subcategory here, let's make it bigger a little bit and see. You can see we have a lot of values, and it makes sense to select all subcategories or deselect, so I'm gonna leave it for that. So that means we just changed that for the category and the country, which is really dimensions with very low cardinality. Alright, so now we're gonna move to the final filter tip that I have for you that I usually use in my projects, which is as well about the design and the look and feeling in Tableau. So here we're gonna use the suitable filter modes in the quick filters. So let's see what I mean with that. First, we're gonna start with the order dates, or with the date that we have usually in our view. I usually tend to use here like a continuous field instead of a list of distinct values. So what I mean with that, I usually go over here on the year of order date, right click on it and convert it to continuous. So with that, we're gonna have like a range between 2 values, which can has as well less space in Tableau. So let's go and switch it. So now, as you might already notice, the order date, the quick filter did disappear because we changed the role from discrete to continuous. So let's go and show it again. And as you can see now, we have the quick filter very minimum and not taking a lot of space. So this is really nice as a start to have a range between 2 values for the dates. Let's move to the next one. We have the country. So the country is dimensions with very low cardinality, and here I tend always to use a list with multiple values. So everything here is correct. Let's check that. So it is multiple values, a list. So I'm gonna leave it as it is. The next one, we have the city. Here we have a lot of values, and here we can only see like 3 values from the whole filter. Doesn't make sense to have it as multiple value list. Instead of that, I was gonna say this is dimension with medium cardinality. We're gonna always tend to use a drop down for that. So I always skip this single value. It's like restriction that has no meaning. So we're gonna go with the multiple value drop down. And with that, as you can see, we have a minimum space. We have only like 1 value that we can see. So if the users want to select the cities, so the user is going to go and select the values that they need and then close it. So it's really minimum and don't take a lot of space. The next one, we have the postal code as well. Here we have the same situation, a dimension with a medium cardinality. We have like a lot of values, so we will not leave it as a list. We're gonna have it as a drop down menu. So as you can see, the size compared to the city is really big in the visualization. So we're gonna go as well over here and change it to multiple values drop down. The next one is the category. It's exactly like the country, only 3 values, very low cardinality. We're gonna leave it as it is. And I think for the subcategory, you already know that it has like medium cardinality. We're gonna go over here and make it a drop down. So now we're gonna move to the last one. We already talked about it. The product name is huge and has a lot of values. The best practices here is to use a wildcard match for this value. And for example, let's take another one. Let's take the first names. So I'm gonna show the filter over here, and we're gonna bring it just down the last one beneath the product name. This as well is a huge filter. It has a lot of values, and here is as well dimension with high cardinality. So we're gonna go and switch the modes to a wildcard match, exactly like the product name. So as you can see, we have now a lot of filters, which is not really good for the performance, but we saved a lot of spaces as we change the filter modes. So with that, we have really nice quick filters on the right side, not taking a lot of spaces. So with that, I covered all the tips and tricks or best practices that I usually use in Tableau projects if I'm using filters. Alright, now we're gonna learn how to sort your data inside Tableau. A lot of people think that sorting data in Tableau is not working correctly, which is not really right. So we're gonna remove now this confusion and we're gonna understand how sorting in Tableau works. So let's go. Okay, so now let's understand what is sorting. It's very simple. So sorting is arranging your data in a specific order. And here we have two options. Either we're going to sort it using the ascending order. Here we can arrange your data in increasing order. That means we're going to start with the lowest, and as we are moving down, we're going to have the highest value. For example, let's take the order ID. We can sort it using the ascending order. Then the value is going to be like this: 1, 2, 3, 4, 5, 6. So the values are increasing as we are going down. Or if we have, like, for example, the first name, we have characters. So it's going to be sorted from A to Z. So for example, we have here Andy, Dwight, and end up with Pam. The second option is to sort your data using the descending order. Here we're going to arrange your data in decreasing order. So that means we always start with the largest value, and as we are moving down, we're going to go to the lowest value. For example, again here the order ID. So we start with the highest value. In this example, it's going to be the 6, 5, 4, and as I'm moving down, I'm going to get the lowest value. The same for the first name. It's going to be the opposite of alphabetical order. So we're going to start with Pam, Michael, James, until we end up with Andy. So as you can see, it's very simple. We have only two options, either sorting the data using the ascending order or the descending order. So now let's go in Tableau and understand how we can do that. Alright, so now let's create another view from the scratch. We're gonna stay with the big data source. Let's take, as usual, the subcategory in the rows, and we're gonna take as a measure the sales. So let's put it in the columns. Let's show the numbers. So I'm gonna take it to the labels and as well to the colors. Then we're gonna have as well in the columns the country. So let's go to the customers. Inside the hierarchy location, we have our country, and let's put it over here. Okay, so this is our view for now. There is two ways on how to sort data in Tableau, either directly in the visualizations and we call it quick sorts, or we can do it as we are building the view as developers. So we're gonna start the first one where we're gonna learn how to do sorting using quick sorts from the visualizations. And this is what usually the users gonna see and do. Alright, so now for quick sort in Tableau, there are three places where you can sort your data directly in the visualizations. The first one is sorting the data from the header. So if you mouse hover on the header name over here, you can see that we have like small icon in order to sort your data. So we can use it here to sort the header informations. Or the second place, we can go to the axis over here, and you can see as well there's like small icon to sort the data. And the third one, the last one, if you go to the field labels, so if you go to any values here inside the header, you can see we have as well small icon to sort the data. So those are the three places where you can sort the data in Tableau. And sorting work with 3 clicks. The first click gonna sort the data ascending. The second one gonna sort the data descending, and the third click gonna bring the data as it is sorted from the data source. Alright, so as a default, the data gonna be sorted as the data source. So if your data source is sorting the data ascending, we can have the same way as the view. So now as a default, we are not enforcing any sorting in our view, but we are taking it from the data source. And as you can see, it is sorted already in ascending fashion because we have that from the data source. So now if you go to the header, for example, let's click on this icon and see what can happen. As you can see, nothing happened in the view because it is exactly like the data source. We have it in ascending fashion. So that was the first click that we done. We sorted now the data in ascending way. And you can see over here, we have a small icon that indicates this dimension is now sorted in the view in ascending way. So let's go again over here and click again. So let's see what's gonna happen. If I click on it, now the data gonna be sorted in descending order, and as well here we're gonna have different icon. So we have the tables and then it ends with the accessories. So now we have it descending. Now to go and reset everything back to the default, to the data source modus, what we're gonna do, we're gonna click the third time. So if I click again over here, the icon gonna be gone from the dimension and the data gonna be sorted exactly like the data source. So this is how sorting in Tableau works. You have 3 clicks, the first one ascending, the second one descending, and the last one we're gonna bring it to the default as the data source. Alright, so now we're gonna go to the second place where we can sort our data in the view, and that is the axis. So if you go to the axis over here, we can find this small icon, and here is exactly the opposite. The first click gonna sort the data in descending order, the second click gonna sort the data in ascending order, and the third one gonna bring it back to the default like now. So let's try that. We're gonna click the first one. As you can see now, the data and the rows are sorted in descending order. We start with the highest sales, and as we are moving down, we're gonna move to the lowest sales. Alright, so now let's click the second one. So let's go. We are now sorting the data in ascending order. So we start with the lowest sales and we end up with the highest sales. And the third click gonna bring it to default without any order. So let's click on that and we are back to the start where the data is not sorted at all. So as you can see with the header and the axis, we are sorting the rows only. So only the rows are sorted. We are not sorting the columns. So France, Germany, Italy, USA gonna stay at the same position. We are not sorting the columns. And now in order to sort the columns, we're gonna go to the third place to the field label. So we're gonna go to any of those values, doesn't matter which one, and we're gonna click, for example, on the chair. You can see this small icon here again, the same as axis. The first one gonna sort the columns in descending order, the second one ascending, and the third one to the default like now. So let's go and click over here on this icon. Now the data is sorted in descending order. So that means the first column gonna has the highest sales, then the next one gonna has the lower, and as we are moving to the right, we're gonna get the lowest value. So we are sorting the columns in descending order, and as you can see as well on the columns, we have this icon over here indicate that the columns are sorted now in the view. So now if you go and click it again, we're gonna sort it in ascending way, where we can start with the lowest value, the first column, and as we are moving to the right, we're gonna have the last one with the highest value, and as well here we can see the icon which shows that the data is sorted in ascending way. And the last click, as you know, we're gonna go back to the default. The data is not sorted at all. Alright, so that's all about quick sorts in Tableau. It's really simple once you understand the places to sort the data and how you can click around to sort the data in different ways. A lot of people get confused about it, but it's really simple. Let's say that we have the following scenario where you say, you know what, I don't want to offer the users this possibility to sort the data. I'm gonna sort everything in the view and the user's gonna just see the report as I prepared it. Alright, so now in order to disable the sorting option for the users, we're gonna go to the main menu and then we're gonna go to the worksheets, and then here we have show sort control. As a default, Tableau gonna enable it, which makes really sense. So now let's go and disable it and see what can happen. Now if you go to the visualizations, you will see that we don't have anymore the icons in order to sort the data. So if I go to the sales over here, or I go to the subcategory or anywhere, you see we don't have any options in order to sort the data. So this possibility gonna be completely disappear for the users. So with that, we have removed completely the options for the users to sort the data inside the visualizations. And to be honest, I've never been in a situation where I have to remove this option for the users. It really makes everything static, and this is exactly the opposite of what we want. We want to make always our dashboards and reports dynamic interactives for the users, and I think it's always really bad to make only static reports without having any dynamic inside it. Unless maybe the users exactly ask for this to say, okay, I don't want to sort the data, make it static as much as you can, so you can go and disable this option. So for now, I'm gonna go to the worksheet. I'm just gonna go and show set control and enable it again. As we go again to the sales, you can see we got again those small icons in order to sort the data. Alright guys, so that's all about how to sort the data directly from the views from the user's point of view. Alright, so now we're gonna move to the second group where we're gonna learn how to sort the data as you are building the view. So in order to do that, there's two ways to do it, either from the toolbar or from the dimension itself. So now if you move to the toolbar, we have here two options, sorting ascending and sorting descending. So now in order to sort those dimensions, you can click on the country, for example. Now we are sorting the columns, and then click over here ascending. So as you can see, now we are sorting the data in ascending way for the columns, and if we want to sort the subcategory, the rows, we can click over here and then click on ascending or descending. So as you might already notice, we are sorting the data always by the measure, by the cells. So if you mouse hover on it, it's gonna say sort subcategory descending by the cells. So we don't have any option here to sort the data by the header, so it only sorts by measures. Alright, so that's it about how to sort the data from the toolbar. The second method is to sort the data directly in the dimension. So let's go, for example, to the subcategory, right click on it, and as you can see we have here two options about sort. We have clear sort and sort. So clear sort gonna reset everything to the default. So let's go and do that to start from the scratch. So I'm just gonna clear everything for the subcategory and then right click on it and let's go to sort. With that we're gonna get a new window says we are sorting now the dimension subcategory. I will just move it to the left side in order to see how Tableau gonna react to my selection. Okay, so what do we have over here is two sections. The first one is about how to sort the data, the sort methods. The second one is about the sort order, ascending and descending. So let's see which options do we have. We have 5 options: the data source order, alphabetic, filled, manual and nested. Let's start with the first one. The data source order, here we have it as ascending, so we are sorting the values inside our header, the subcategory, in ascending way in alphabetical order. We can reverse it by going to the descending order, so as you can see the value is gonna switch. Now if you want to go and reset everything, we can go over here and click clear to go to the default settings, and that's it for the data source order. Let's move to the next one. We're gonna have exactly the same effect because we have it as well at the alphabetical order. So let's go over here. As you can see, nothing gonna change because we have it at descending, and let's go in alphabetical order to the ascending, and the header gonna switch, so exactly the same effect. Alright, so now let's move to the third one. We're gonna go to the field, and now we can go and sort the data by any field from the whole data source. The field doesn't have even to be on the view, but of course it makes no sense to do that. So here as a default, Tableau is selecting the sales because it's only measure that we have in the view. It makes sense, and the data is sorted in ascending way. But if you want, you can go and sort the data by the number of customers inside each category or subcategory. So we can go over here and select the customer ID, and the function gonna be count, so the total number of customers inside each category. So now those categories are sorted in ascending way depending or based on the total number of customers. So we have this ability to sort the data by any field from the data source, but it doesn't make sense of course to sort the data like this because it's gonna confuse the customers and they will not understand why those categories are sorted like this without having like a description in the report. So that's all for this method, sort by field. Let's move to the next one. We have sort by manual, and here you have the freedom to make the order of the dimension. So for example, we can take these machines over here, and as I'm moving it down, you can see the order in the view is changing as well. So I can go and sort the dimension as I want. So it's really simple. Here we don't have any rules. We don't have ascending or descending. We have the complete freedom to sort the values inside any dimension. And that's it for this option. Let's move to the next one, and the last one. We have the nested. Now in order to understand how the nested sort works in Tableau, we have to work with multiple dimensions. The best way is to get hierarchy. So now let's go and create another view. So I'm just gonna go and close this one here. Let's take the continent to the rows, and let's take the profits to the columns. And as well as usual, we're going to show the labels of our data. Now if you go to the continent over here and right click on it, let's go to the sort, and let's say we're going to sort the data by the data source descending. As you can see, we are now sorting only the continent, and if we drill down to the country, you can see that only the continent is sorted, but the country is not sorted. So if you go as well to the city, you can see that the city is as well not sorted. Only the first dimension is sorted. But now instead of that, we can go and use the nested sort in order to sort all dimensions inside the hierarchy automatically. So let's go and remove those stuff. So I'm just gonna drill back to the continents, or we call it drill up. So right click on it and let's go to sort, and then we're gonna go to the nested, and now we're gonna say okay, so the data ascending, and we're gonna use the measure, the aggregation sum of profit in order to sort the data. So now let's go and close it, and with that we got the nested sort. As you can see, the continent is sorted, but now if I drill down to the country, let's see the country gonna be as well sorted. So now if you look closely to the data, you can see that the USA is the only country inside this continent, so we cannot see any sort over here, but you can see that the countries in Europe are sorted ascending. So it starts with the lowest value from Italy, then France, then Germany. So you can see the country inside this continent is sorted as well based on the nested sorts. So as you can see, the countries of each continent gonna be sorted separately from the countries from the other continents. So this is how the nested sort works. Let's go and just put the profit and the colors as well. So now let's go down in the hierarchy and drill down to the city. We're gonna have more data and it's gonna be more clear. As you can see now, the city is as well sorted, and now we are sorting the cities in one country. So for example, over here in USA, the lowest sales is in Seattle and the highest sale is in Portland. So we are sorting the cities based on the country. So this is one section, the next section is Italy, the next one is Germany. So each country gonna be sorted separately from other country. So with that, we have learned this method work if we have multiple dimensions, and it's gonna work perfectly if we have hierarchy in our view. Everything gonna make sense and the sort gonna be very logical for the users. So as I'm drilling down, for example, to the postal code, or I'm rolling up back in my view, everything gonna be sorted in very logical way. Alright guys, so with that we have covered everything. How to sort the data inside our views from the user's perspective, how to sort the data as we are building the views, and I think it's really simple and not that complicated. Alright, so that's all about how to sort our data in Tableau, and we have completed this section. In the next section, we're gonna learn about Tableau parameters to add dynamics to our visualizations. Alright everyone, so now we're gonna talk about the parameters. Parameters are game changer in Tableau, and that's because, and this is my opinion, parameters are the best feature that Tableau did introduce, because parameters in Tableau gonna make your visualizations very dynamic, interactive and flexible in very unique way that you cannot find it in any other BI tool. Alright, so now what are parameters? Parameters are like variables in programming languages that allows user to replace a constant value in the calculations, filters, a reference line, and so on. Okay, so now what this really means, if you are building a view for your users, you are already making a lot of decisions, defining a lot of values that can stay static, and the users are allowed only to read your views. So for example, you might create the following calculation in Tableau, where you are defining a threshold for your KPI. So you are saying if the total sales is less than 400, then the KPI gonna show red, otherwise it's gonna show green. So here the value, the threshold 400 is static and cannot be changed from the users, the viewers, only can be changed from the developer. But now you might be in a situation where you have two requirements from two different users where they define different thresholds. So here you end up making two calculations for two customers and as well creating two views. But now instead of doing that, we can use the power of parameters. So here we're gonna replace the value 400 with a parameter, and then we're gonna offer the parameter as an input field for the users in the view, and now the users can use the parameter to define the needed value as it requires. So using parameter gonna change the behavior of your view depending on the value of the parameter. This gonna make your views are dynamic and ready for any requirements. And there are endless ways to use parameters in Tableau, and in this tutorial I'm gonna show you 6 different use cases. The first use case is about how to use parameters in calculations. The second use case is about the reference lines, the third one how to use them in filter, and we have another very special use case on how to switch between dimensions and switch between measures in very dynamic way in one view, and another use case about the titles and text, and the last use case how to use parameters in pens. Alright guys, so now let's start with the first use case, how to use parameters in calculations. So now let's create now some kind of KPI to track the profits by the subcategory. Okay, so now we're gonna stay with the big data source and we're gonna go to the product to get the subcategory, and then we need the measure profits. So we're gonna go to the orders and we're gonna get the profits over here. Okay, so now we're going to show as well the labels on the view, and now we're going to have a threshold or KPI where we're going to say if the profit is less than 10k, then it's going to be red, and anything higher than 10k is going to be green. And now in order to create the logic and the colors in the view, we have to create calculations. Don't worry about how to create calculations in Tableau because we're going to have a dedicated section for that. So now in order to create a calculation, we're going to go to the data pane, right click on the empty space, and then choose create calculated field. So let's go there, and now we're going to call it KPI colors. And now then we're going to write here the expression about our logic. So it says if we need sum, and then we have the profits. We said if it is less than 1000k, then it's going to be red. So we're going to write the value red. Otherwise, it's going to be green. So Let's end it. So with that, we have our logic for the colors in our view. And as you can see over here in our calculations, we have a constant. It is the 10K. So let's go and create that. So we're going to click OK. And here on the left side, you can see our dimension. We're going to take it and put it on the colors. And now let's go inside and assign the values for the colors. So green, it's going to be green, and red, it's going to be red. So let's click OK. So now we can go and give this report to the users and they can view it and interact with it. But now, as you can see, the calculations of the KPI is really static and they cannot customize it. In order now to give to the users the option of defining what is red and what is green, we have to use parameters. And now in order to create parameters in Tableau, there is two ways to do that. Either you go to the data pane and create your parameters, or you create it in the place where you need it. For example, if you are creating a filter, so inside of the creation of the filter, we can create parameters. So now let's see first how we can create parameters in the data pane. So in the data panes, there is two ways to create parameters. Either you go to the empty space and right click on it, then you can see here, create parameter. Or the other option is that you go to the head of the data pane and you have here small arrow. So if you click on that, you're going to see exactly the same drop down. And here we have the option of creating parameter. So let's select that. And now we have the window of creating parameters. So first thing first, we have to give it a name. So we're going to call it choose threshold. Next, we have to define the data type of the parameter, and if you go over here, you can see a list of all data types. But here you know all of them, but Tableau here decided to go with float and integer instead of number whole and number decimal, but they are exactly the same. So for now, we're gonna go with the integers. We don't want to have decimal numbers in the KPI. And then once you do that, we can define the display format. And here for each data type, there are different formats to represent the values. So as you can see, we have automatic, number standards, percentage, currency, customized. I'm gonna stay with the automatic. And then in the next one, you have to define the default value that's going to be show up in the input. So here I would say it's going to be the 10,000. And of course, the users can change that. Then after that, you have different options to limit what the users can select. So the default option here is all. That means you are allowing the users to enter any value. But of course, we limited the data type to integers. That means the users cannot go and enter any characters in the input field. Or you define for the user a list of allowed values. So here you can go and allow, for example, 5 different values. Maybe to make sure that nothing goes wrong in the view. So here you are making the parameter more restrictive. So the list is something like discrete. You are allowing a list of distinct values. And the next one is something like the pins. You are defining the start and the end of the range. And then you are defining the steps between those two values. So for now, I'm going to leave it open-ended so the users can select whatever they want. All right, so now let's go and hit OK to create the parameter. And now if you check the data pane on the left side, let me just minimize those tables. You can see that the parameter is going to be created always at the end of the data pane. So there is like a separator between your data and the parameters. And that's because the parameters are something that is independent from your data source. So there is no dependence between the parameters and your dataset. It's completely something independent and only special for the workbook. Okay, so now we have the parameter. How are we going to show it to the users? So in order to do that, it's really easy. Go to the parameter, right click on it, and then we have the option of showing parameters in the view. So let's select that. And now you can see the parameter input on the right side of the view. So here we can see the value of 10K as a default. So now let's go and change the value. We're going to have it like 500. You can see nothing changed in our view. So does it matter what you are giving here? You see that the view is not changing. So that means we have now to connect it somehow to the view. And in order to do that, we're going to go inside the calculations and replace the constant value with the parameter. So let's see how we can do that. So we're going to go to our calculation, the KPI colors, right click on it, and then let's go to edit. So now we have to go over here and replace this value. So I'm going to remove it. And now we're going to type the name of the parameter. As you can see, Tableau going to suggest us here. And click on it. So with that, any values that the user is going to give for this parameter going to be used directly in this calculation. Let's try that out. Gonna click OK. So as you can see, something changed already in the view, but let's go and play with the values. Instead of 5K, we're going to have like 20K. Let's OK. And with that, I just changed the threshold for this KPI. So now anything below 20K gonna be red, anything higher gonna be green. Let's have another value like 50K. And now as you can see, the threshold is really high. We have only 2 values with green. And as you can see, it's very dynamic and you give the users the power of defining and customizing the KPI as they want. And with that, you're gonna cover a lot of requirements in only one view. I just love this feature in Tableau. Alright, Alright, so now let's see another use case of the parameters. We can use parameters in the reference line. So we can show in our view a reference line to indicate what is the thresholds. Just it makes it more clear where is the cut between red and green. And here we can use our already existing parameter to show the threshold in the reference line. Let me show you quickly how we can do that. So now let's go to the analytics pane, and then here we have the option of creating a reference line over here. So let's go and double click on it. And now we have a new window to configure the reference line. There are a lot of options, but now we're going to focus on the parameters. What is really here important is the value of the reference line. So now let's check the option that we can see over here. And as you can see, Tableau here is suggesting the metric. The second one is to create a new parameter. The third one is to choose the already existing parameter. So as you can see, we can create a new parameters exactly in the place that we need it. But for now, it makes really sense to use the same parameter in the reference line. So let's go and select that. And now as you can see on the right side, we have already a reference line in our view, and we have the label of choose threshold. So instead of showing the labels, we're going to show the values of the parameter. In order to do that, we're going to go to the labels and we're going to change this to value. So let's select that, and that's it for now. Let's go and click OK. So as you can see, we are showing now the threshold as a reference line. And if we go and change the value of the 50K to, let's say, 10K, let's go. So now as you can see, the user can control everything in the view. With their input in the parameter, they are changing the calculation as well the reference line. It's really cool and professional to have this dynamic on your reports. So this is how you can use the value of the parameter inside the reference line. Alright, so now we're gonna go to the next use case where we're gonna use the parameters in filters. And we're gonna learn as well how to create parameters exactly in the place where we need it. So now we're gonna go and create a report where we're gonna show the top 10 products in our datasets. So in order to do that, we're going to stay with the big data source, and let's go to the products and we take the product name. So double click on it. So now we have a list of our products, and what do we need is a measure. So we're going to go to the orders and we're going to take the sales. So drag and drop it over here. As usual, let's have labels, and I'm going to sort it descending. And now we want to show only the top 10 products. And in order to do that, we're going to take the product name in the filters. So we can drag from here by holding Control and then drop it on the filters. So now in the filters over here, we want to show the top 10 products. In order to do that, we're going to go to the tab top. And now we're going to go and define the rule. Everything is fine. So here you can see top 10 by sales. So now as you can see, we are defining a rule. And in this rule, it's like the calculations. We have a constant. And the constant in this rule is the 10. So now you might be in the same situation where you have one user asking for top 10 products and another user asking for top 20 products. So now instead of going and creating two different filters, two different views, we can stay with the same view and use parameters. And then you're going to give the end users to define their list. So now we have to change the value of 10 to parameter. So let's click over here, and here you have always the three options. Either the value you enter, or you can create a parameter or use already existing parameter. So now we want to create a new parameter for this view, and as you can see, this is the second method on how to create parameters. So we will not go to the data pane, we're going to create it exactly where we need. So let's go and click create a new parameter. So now we have here again the same window where we're going to create a parameter. We're going to call it choose top n products. And now you might notice that you cannot change the data type because you are creating here a parameter inside the filter for the sales. And the sales is measure and a number. But the same here, you can customize the display format, the current value, and as well which values you can allow, whether everything or a range. So now let's try the range. The minimum going to be 1, the maximum going to be 50, and we're going to have a step size of 5. Alright, so that's all. Let's click OK. So now let's check again the rule. We have top, then our parameter by sales. So that means we don't have a constant value and we are using the parameter. Let's go and hit OK. So now as you can see, the report is showing the top 10 products because the default value of the parameter is 10. And if you check the left side, we have a new parameter called choose top n products. Great. So now the next step is to show the parameters for the users. So right click on it and say show parameter. All right. So now let's check our parameter. Now it's showing 11. I thought I gave it like 10. So let's edit it again. Right click on it and then let's go and edit. Alright, because we played with those values. So as you can see, it's like pins. It starts from 1, 6, 11, and so on because the size is 5. So what we're going to do is to change this to 0. And then as you can see, we have here again a 10. So let's click OK. Alright, so now I promise you we have top 10 because if you check the value here on the parameter, it's 10. Alright, so now this is something different. Instead of having input fields, here we have like a range slider. So the user can change the slides. And as you can see, our filter reacted and it's showing now the top 20. Or the users could use those arrows in order to change the step. And as you can see, as I'm moving to different values, the filter size as well is changing. So that's it. This is how you can use parameters and filters. As you can see, your view is very dynamic and you let the users to customize what they want. Alright guys, so now we're gonna move to the most important use case in parameters. You're gonna see this use case almost in each Tableau project. So the use case is to use parameters to switch between dimensions and to switch between measures. So now let's learn first how to use parameters to switch between dimensions in one view. So let's say that you are building a dashboard about the sales and you're gonna have views like sales by country, sales by category. So that means you are creating two views with the same metric but different dimensions. So now instead of having two views, we're gonna have only one view for the users and they're gonna decide which dimension they're gonna use in the view. And now in order to do that, we have to use the power of parameters. Alright, so now let's go and create our view. We have the sales, so let's take the sales on the columns, and then we need the countries. We're going to take it from the customers, and then we have here the country in the rows. Great. And as usual, we're going to show the labels. So now we want to make the dimension country as a variable, as parameter. So that means we need somehow to switch between dimensions, between country and category in the same view. So that means instead of having the dimension country, we want to have like a dynamic dimension with different values. So now the first thing that we have to do is to create a parameter where the user is going to choose which dimension should be presented at the view. So here we're going to go and create a parameter from the data pane. So click over here, then create parameter. So here the main focus of this parameter is to choose which dimension can be presented at the view. So first let's give it a name. We're going to call it choose dimension. And now the question is, what are the values inside this parameter? It's going to be the dimension name. So it's going to be values like country and category. So they are string. So the data type over here is going to be string. Let's go and select that. And as you can see, Tableau did disable the format. We cannot choose a format for the string. It's like free text. Next, we have to define the current value. And here we're going to have the dimension country as a default. So let's go and enter the value of country. All right. So now since the data type is a string, we cannot build a range from it. So here we have only two options. Either we're going to have it as a free text as an input field, and in this scenario it really makes sense to have a predefined list for the users, since the users will not see your data source and they have no idea which dimensions do we have. So for that, if we go with the free text, it's going to be really confusing and no one gonna get the right dimension for it. So in this scenario, we really must provide a predefined list for the users, and then they're gonna select the value that it's gonna suit them. So here in this example, we're gonna offer only two dimensions. It's the country and the category. So let's go and add those values. So we're gonna have the country, and the next value gonna be the category. And of course, you can add more dimensions like the city, the product name, and so on. So now we're going to stick with the example, and that's it. So let's click OK. Great. So now if you check the data pane, we have a new parameter called choose dimension. And here you can see quickly which data type do we have for each parameter. So now the next step is to show the parameter for the end users. So right click on it. Let's go and show parameter. All right. So now let's check our parameter. On the right side, we have a list. It makes sense. We have created a list parameter, and at the end, we're going to have a list for the users. And inside it, we have only two values, country and category. So now if you go and switch between those two values, nothing gonna change in the view because this parameter is not yet connected to our view. Alright, so now we're gonna go and create our dynamic dimension and use it in the view instead of the country. So that means we have to create a new field. In order to do that, right click over here and create calculated field. So let's go there. Now let's call it dynamic dimension. We're going to use here the case when. Don't worry about it. I'm going to explain everything in the section of calculations. The syntax starts with case, and then we have to specify the field name. And in this situation, we're going to enter the parameter. So our parameter called choose. And here, as you can see, as you are writing, Tableau is suggesting stuff for us. So our field called choose dimension. So next, we're going to go and specify an action for each scenario, for each value. So let's have a new line and write when. The first value going to be the country. You need to be really careful here to write it exactly as we wrote it in the parameter. So it was capitalized in the parameter and it should be as well here capitalized. Otherwise, it will not work. So now what can happen if the value is country? Then we have to specify the action. So if the users chose country, what can happen? The dimension country should be used. So let's go and write over here country. And as you can see, as I'm writing, Tableau is suggesting. So we need the dimension country. You can see it from the icon over here. So let's select that. All right. So now let's move to the next scenario is that the user gonna go and select the value of category. So it's exactly the same stuff. We're going to write here when the value is category. Then what's going to happen? The dimension category should be used. So let's start typing here category, and as you can see, we have suggested over here the dimension category. Let's select it. So that's it. This is the scenarios that could happen to the parameter, and we have to end the case when like this. So as you can see in this calculation, we are just mapping between the values of the parameters and the dimensions. So let's go and click OK. Now, as you can see, we have a new dimension on the left side called the dynamic dimension. It is calculated field. And now we're going to go and remove our static dimension, the country. And instead of that, we're going to add our new dynamic dimension. All right, so now let's go and check whether it's going to work. As you can see, the value is now category, and in the view, we see the categories, which is really good. All right, so now let's change the value of the parameter to country. As you can see, the dimension in the view did change. So now we have country instead of category. So as you can see, parameters are really powerful, and you are going full dynamic in your view, where the user is going to define the level of details in the view by changing the dimension. So imagine now you are making a dashboard with sales and you have 10 dimensions. Here you are going with only one view instead of having 10 reports. Alright, so that's it for this use case. This is how you switch between dimensions using parameters. Alright, so now you have the following Tableau task. The task says to create a dynamic measure using parameters to swap between 3 measures: sales, profits, and quantity in the same view. You can pause the video right now to do the task, then resume once you are done. Alright, so now let me show you how you can do that. We have exactly the same steps as the dimensions. We have first to create the parameter, and second to create the logic in the calculated field. Let's start with the first one. To create the parameters, we're going to go to the data pane, click over here and create parameter. We're going to call it choose measure. And here you have to think about the values of the parameters. So it's going to be the name of the measures, which means the data type going to be a string. And here we have to define the default value. So here we have 3 values: sales, profit, and quantity. And we're going to have the default value as sales. And here again about the values, the users don't know about your data source. So they don't know the exact name of your measures. So you have to go and create a predefined list for them. So let's go over here. We have 3 values. So we're going to have the first one, sales, the second one, profit, and the third one going to be the quantity. So that's it. Let's go and hit OK. So as you can see on the left side, we have our new parameter, and the next step is to show the parameters for the end users. So in order to do that, right click on it and show parameter. So let's check our parameter over here. You can see it starts with the sales since it's our default, and you can switch between those values. But as you can see, nothing is changing at the view. So the view is still showing the sales. So the next step is now to go and create the calculated field. In order to do that, we're going to go to the data pane, right click over here, and then select create calculated field. We're going to call it dynamic measure. And here again, we're going to use the same syntax. So case, then the name of the parameter. So choose, we're going to select the measure. And now we're going to go and define the scenarios. So when the value is sales, then the action going to be selecting the measure sales. So write sales and select the measure. All right, so new line, and we're going to go now and map the next value. So it's going to be the profit. Then the measure profit. So profit, and let's go and select the measure. All right, so we map that. We're going to map now the last value. So we have the quantity. And if the user select this value in the parameter, the quantity measure is going to be selected as well. So let's go with that. So that's it. This is our 3 scenarios. We're going to have end at the end. So now as you can see, our calculation is valid, and let's go and hit OK. And now if you check the data pane, we have new calculated field called dynamic measure. So now what we're going to do, we're going to go and remove our static measure and replace it with the dynamic measure. All right, so now let's go and change the values in the parameters. So let's start with the sales. As you can see now, we have the values of sales, and if we switch it to profit, you can see the axis and the values in the view are changing to the new measure. But now let's go to the last one, to the quantity, and as you can see, we don't have any data. Well, if you have something like this, then we have an issue either in the calculations or in the parameter. So let's find out where is the error. Let's go to the calculation again, right click on it, and then go to edit. And here we have to compare the values. As you can see, we have here quantity and we have the dimension quantity. Everything is like correct, but as you can see, the value over here in the parameter is quanti. So here I have a typo, and that means for Tableau, we didn't define any scenario for this value. In order to correct that, we're going to go to the parameter on the left side, right click on it, then go to edit, and then we're going to go to our list and change this value. So double click on it and write it correctly, quantity. So that's it. Let's go OK. And now, as you can see, we have data for the quantity. So it's really important to have exactly the same values from the parameters inside the calculation. So as you can see, it's really sensitive. So with that, we have a dynamic dimension and a dynamic measure, and we can switch between those stuff as the user wants. Alright, so this is how you can use parameters to swap between measures in a view. It is just great. Alright, so now we can move quickly to the next use case where we can create dynamic titles using parameters. Now, if you look to our previous example, we have an issue. You see, we have the title sales by country, but the view is showing category by profit because we chose over here category by profit, and now the title is wrong and misleading. So how we can solve this problem? We can use parameters to switch this static title to a dynamic title. Let's see how we can do that. So let's go to the title and double click on it. And now we have a new window to customize the title. And now the role as a default, it's going to be the sheet name. So that means the name that you give to the worksheet gonna be the title of your view. So in this example, I call this worksheet as sales by country, and we have it as well as a title. But now we have to change this rule to be measure by dimension. Let me show you how to do that. So let's just remove this rule, and the first word in our naming convention gonna be the measure. And now in order to insert the parameter, we're gonna go over here on the insert. Then you will have a list of different Tableau functions, and we have here a section for all parameters. So here we need the parameter for the measures, so let's click on that. And now the next word in our naming convention gonna be by, so space, by, space. So now as you can see, by don't have any background color because it is static, and the parameter has a gray color to indicate that this is a dynamic value. And then the last word of our title gonna be the parameter dimension. So let's go and insert that in the same way. Click on insert, and our parameter gonna be over here. Parameter choose dimension. Let's click on that. So the first word gonna show the value of the parameter measure. Then we have by. Then we have the value from the parameter dimension. Let's go and click OK. And now as you can see, the title of our view did really change. So now we have it correct. Profit by category. And now as usual, we're going to go and play with the values of the parameters. So now let's have the dimension country, and you see now we have profit by country, and the same for the measure. We can go and select quantity. So we have quantity by country. So as you can see, it's really amazing, and you can add parameters in everything, and you're going to have really awesome views in Tableau. Let's have quickly another example. We can do the same in the parameters and filters, and here we can make as well a dynamic title. So let's double click on the title. Let's remove this part. We're going to call it top. And then the value going to be from the parameter, so it's going to be top 30, top 40, and so on. So we're going to go and insert the parameter that you are using in the filter. So it's going to be the choose top end products, and then we can add the word products. So that's it. Let's click OK. And now as you can see, we have the title top 30 products because the value in the parameter is 30. And as you are changing the values in the parameters, you can see the title is as well changing accordingly. I just love parameters in Tableau. Alright, so now we're gonna move to the last use case. We're gonna use parameters in pins. In the last tutorial, we created pins and histogram about the scores of the customers, and we have decided that the size of the bin is 10. So let's go and rebuild this view quickly. It's really easy. So let's take the scores and put it in the columns, and then we're gonna take the count of the customers and put it on the rows. So with us, we have an histogram, and the size of each of those pins are 10. So again, we have a constant value inside our view. Let's go and make it dynamic. So we're gonna go to our pin score, right click on it, and then edit. So here you can see the size of pins is 10. This is what we have defined. But now instead of that, we're gonna create a parameter. So right click on it. And again, we have here the option of creating a new parameter. So select that. Now we're gonna call it choose size of pins. And now here again, Tableau did decide on the data type. It should be based on the scores. And here we have the default value is 10. I'm fine with that. And now we have to go and choose which values can be allowed, either all the values or list or range. And here I recommend to use the range, because if you look to the parameter of range, it really looked like small pins. And as well, it makes sense to define the range for the users. So here we have the minimum 5, the maximum 25, and the step size going to be 5. I'm fine with that. I'm going to leave it as it is. So let's go and click OK. And now you can see instead of having the size of pins 10, we have a parameter. Let's go and hit OK. So as you can see, nothing's changed in our histogram because previously we have the size of 10 and the default value in the parameter is as well 10. So let's go and test everything. We have first to show the parameter. So right click on it and show parameter. So now in the right side, we have 10. And if we are just moving between those two values, you can see that our histogram is as well changing accordingly. And with that, the customers can go and customize the histogram as they want. And here always don't forget to make a dynamic title because it's really cool. So let's go and do that. Double click on it. So as usual, we're going to remove this from here and we're going to call it histogram. So this is the static part, histogram score. And now we're going to add the size of pins. So we're going to have insert size of pins, and then we're going to close it. So that's it. With that, we have a dynamic name. And now you can see the selected value from the parameter is now showing in the title. So if the user is changing the size of pins, as you can see, the title is as well changing accordingly. This really makes a lot of fun working with Tableau. Alright, Alright, so now let's summarize. I think parameters are the best feature that we have in Tableau, and parameters are like variables that allows the users to replace the constant value in the calculations, filters, reference line, and so on. And another unique thing about the parameters is that they are independent from your datasets, from your data source. And the main purposes of parameters is to make your visualizations more interactive, more flexible and dynamic, and give different users the possibility to customize the visualizations for different ways and requirements without having to create multiple versions of the same visualizations. I just love parameters. Alright guys, so with that we have learned everything about the parameters and how to make our views dynamic. And in the next section we will learn more techniques about interactivity in Tableau, and we're gonna focus on Tableau actions. Tableau actions. They are a really great feature in Tableau where it's gonna add more interactivity and dynamic to your dashboards, which is gonna make your dashboards very modern and interactive, and as well it's gonna enable the users to do data explorations using your dashboards. So as usual, first we have to understand the concept behind the Tableau actions, then we're gonna go and practice in Tableau. So let's go. Alright guys, now we're gonna start with the first question. What is action? Well, action is a change of status. That means because of specific event or trigger, the status of an object gonna change from A to B. And the object in Tableau gonna be the visualizations. The starting point, we call it in Tableau, is source sheets, and the action gonna be triggered by the user interactivity. How usually the users interact with our views? Using the mouse. So either by hovering the mouse on the data or by selecting or clicking on the data, and the last option is using the menu. So far we have defined for Tableau the starting point, the source sheet. The second thing we defined for Tableau, what gonna trigger the action. And the last thing that you have to define for Tableau is what can happen once the action is triggered. And here we have 6 different options or actions. The first one gonna be go to URL. That means Tableau gonna jump from Tableau to an external website. So that means the target gonna be here a website, not Tableau or not any visualizations. The second option is to jump or to go to another worksheet or to another dashboard. So here we are moving from one worksheet to another. Moving on to the third one, we have the filter action. What this means, the actions that you are doing at the source sheets, it's gonna affect the filtering in the target sheets. So anything that you are clicking on the source sheets, it's gonna impact the filter in the target sheet. And then we have another action called the highlight. So here again we have a target sheet, and this time any action that you are doing on the source sheet, it's gonna impact and gonna be highlighted in the target sheet without filtering the data. So that means go to sheet, filter and highlights, you have always to specify the source sheet and the target sheet. And then we have 2 other actions where it's going to impact the values of something. So here we have change set value. So anything that you are doing on the source sheets, it's going to affect the members or the values of the target set. So this is going to make the set very dynamic and interactive. The last one we have change parameter values. So again here, any interaction that you are doing in the source sheets, it's gonna impact the values of the parameters. So with that, we have now all the options that you can define as a consequence for the action. So as you can see, it's really easy. We have to define the source sheets, we have to define the trigger, and then we can define what can happen once the action is triggered. Alright guys, so in Tableau we can create actions either in the worksheet page or in the dashboard page. In order to do that, we're going to go to the main menu over here. We can find the option worksheets. So let's go there, and then we have here the option of actions in order to create new actions. Or we can go to the dashboards, and as well we have the same option actions here, but since we are now at the worksheet page, it is grayed out. So now we're going to learn how to create actions in the worksheet page, and we're going to start with the go to URL. So let's go back to the worksheet in the main menu, then let's go and click on the actions. With that, we're going to get the first window. So what we're going to see at the start is an empty table because we didn't create any actions yet. But once you start creating actions, you will get a list of all actions that you have inside the workbook or inside the sheet. So now in order to create a new action, we're going to go over here, add an action. Then we're going to go to URL. So let's select that. And here we're going to get a new window in order to set up our action. In our example, we want to jump from Tableau to external web page to Wikipedia. So we have to give it first a name. The name of the action is going to be go to more details. Then as we learned, we have to specify for Tableau 3 things. First, we have to define for Tableau the source sheet, the starting point of our action. Then we're going to specify for Tableau what can trigger our action. And then at the end, we have to specify the target. So let's start with the first one. We have to specify which worksheet is going to be including this action. So here we have to select first which data source. It's going to be the big data source, and Tableau going to select immediately the current worksheet. So sales insight source. So that's all for the source sheets. Then we have to specify for Tableau what can trigger our action. And here we have 3 options, either mouse hover, select, or by menu. Let's leave it as a menu first. Then we have to define for Tableau what is the URL targets. In our example, we have to specify here, for example, the Wikipedia page. And here we have 2 options, either we're going to create a new tab or we're going to create a new window. So that's all. It's really easy. All what you have to do is to specify the starting point, what can trigger our action, and what can happen once the action is triggered. So let's go and hit OK. And with that, you can see we have now 1 action in this table. Let's go and hit OK again, and let's test it. So far, nothing changed in our visualizations. As you can see, we have the subcategories by the sales. But now once the users clicks on the marks, so for example, let's go on this chairs over here, we will see here a new link. It says go to more details, and this is exactly the actions that you have defined. So here the interaction from the users, they have to go to the marks, they have to click on the mark and then go to the menu. So once click on the link over here, Tableau gonna jump to a Wikipedia page. So that's it. This is how it works. Now let's go and try different triggers. So I'm just gonna close this. Let's go back to the worksheets and then go to the actions. Let's go to our action over here and go edit it. And now instead of using menu, I would like to have select. So let's see the effect of that. Let's click OK and then again OK. Now the trigger for the action gonna be by selecting, by clicking on the marks. So once I click somewhere over here, let's go to the storage. I'm gonna go and click on the mark. We're gonna go and jump to Wikipedia. So as you can see here, it's a little bit more sensitive. Once you click on the marks, you're gonna jump to the URL. So here we don't have a menu where we have a link. We're gonna jump immediately to the link. Let's go and try the hover. It's gonna be more extreme. So let's go to the actions again, to our action, and then let's go to the hover. And here you have to be careful as you are mouse hovering because you're gonna creating a lot of web pages. So let's go and hit OK. Now very carefully, once I mouse hover on the paper, Tableau gonna go and jump to Wikipedia. I didn't click anything, I just mouse hover. So as you can see now, the action is very sensitive to the user's interactions. By just mouse hovering on the marks, Tableau gonna go and execute the action. So with the menu, the users have the chance to think whether they want to execute the action or go to the URL or not. With the select, it's more aggressive, where the user is going to select on the mark, they can jump immediately to something else. With the hover, it's very aggressive. Just by mouse hovering on the marks, the action can be triggered. So now let's go close this and be very careful where you are mouse hovering, because once you hit any marks, Tableau going to go and open a new web page. So let's go back to our worksheets and then go to the actions. Let's remove it because it really doesn't make sense to have a mouse hover to go to any URLs. The best way is to do that is to go to the menu. Alright, so now since we are working with the URLs, we can add a lot of stuff like values, filters, parameters to the URL in order to make something more dynamic. For examples, I would like the users, depends on which subcategory they select, they're gonna go and find more descriptions about this subcategory. So how we can do that? First, we're gonna go to the URL over here and we're gonna add wiki. Then we have to add the value of the subcategory. In order to do that, so let's go to the insert over here. Then we will get a list of all fields that we have inside our data source. So we are searching for the subcategory and we can find it over here. So let's go and select on the subcategory. So as you can see, it's like dynamic inside our URL. And now I would like to make the name of the link as well more dynamic. So let's go and call it read more about, and then we have to add the subcategory to make it more dynamic. So we have as well here an insert, and we're gonna go and search for the subcategory. We have it over here. So that's it. With that, we have a dynamic name for the link and as well a dynamic link. Let's go and hit OK and try that, and again OK. So let's go for examples to the tables over here. Click on the mark and you can see here we have the following link. It says read more about tables. So it reads the value from the subcategory that we are currently selecting. So let's click on that, and here we're going to jump immediately to the Wikipedia page that describes the tables. Let's go and try something else. Let's go to the storage over here. As you can see, the name of the link is very dynamic. We have read more about storage, and once you click over here, you will get more information about the storage. So this is really amazing in order to add more context, more informations inside our visualizations and to make it more interactive. So that's all now for the go to URL action. Alright guys, next we're going to learn how to use actions in order to jump from one worksheet to another one. In this example, we have the source or the starting point, the sales insights, and the target going to be the profit insights. So now we'd like to make an action in order to jump from the sales to profits. In order to do that, we're going to go to the worksheets in the main menu, then we're going to go to the actions, and we're going to go and create a new action. This time we're going to go and select go to sheets. So let's go and select that. And here we got our new window in order to set up the action. It is very similar to the URL setup. So first we have to give it a name. We're going to call it go to profit insights. And then here we have the three things: the source, what's going to trigger the action, and the target. The source is going to be the sales insights, and the action this time going to be as well by menu. Let's go and select that. And then we have to specify the target sheet. It's going to be the profit insight. So let's go and select that. So we have our setup. Let's go and hit OK. That's all. Then as you can see, we got a new action in our table. Let's go and hit OK as well. So now let's go and test it. Let's go to one of those marks. Let's go to the machines, and then we get our menu. So we have now two links. The first one says go to the profit insights or read more about the machines. So this one going to take us away from Tableau to an external web page. The first one going to move us to another worksheet inside Tableau. So let's click on go to profit insights. Now as you can see, Tableau executed the action once we clicked on that, and we jumped to another worksheet. Now we are at the profit insights. All right, so that's it. As you can see, it's really easy. We have to just specify the source sheets, the target sheets, and what can trigger the action. Alright guys, moving on to another type of actions, we have the filter action. So what can happen here, that's anything that you are selecting in the source sheets, it's going to be relevant in the target sheets. That means in the target sheet, we will see only the data, only the informations that you have selected in the source sheets. So let's see how this works. We're going to stay with the same examples where we have one worksheet about the sales, it's going to be our source, and we have another worksheet about the profits, it's going to be our target. So let's start with the source. Let's go to the menu, worksheets, let's go to the actions, and let's go and add a new action. The first one going to be the filter. So let's go to the filter. Here we get again a new window in order to set up our filter action. It's going to be very similar to the previous ones, but here we have a little bit more options. So first we have to give it a name. We're going to call it filter profit insights, and here as usual we have to define the source sheet. It's going to be the sales insights. I don't want to have all sheets. And then the trigger is going to be, let's say that's going to be the select this time. And then we have to define the target sheet. It's going to be our profit insights over here, the filter. So here in the filter actions we have more options about the interactivities. We have to define for Tableau what can happen once the users deselect the data, once they clear the selections. So here we have three options: keep filtered values, show all values, exclude all values. The best way in order to understand this interactivity is to have an example. So now we're going to stay with the default keep filtered values. Let's go and hit OK. With that we got our new action over here. Let's hit OK again and try the action. The best way in order to understand how this filter action works is to bring both of the worksheets in dashboards. So let's go and create a new dashboard, and let's go get the source and get the target as well below it. I will just remove this legend over here. So now let's go and start interacting with the report. So again here, once we select something from the source, it's going to affect the data on the targets. So for example, let's go and select, for example, those subcategories. So as you can see, my interaction with the source is going to have an effect on the target. Now we can see only the subcategories that I have selected in the source sheets. So with that, the user is going to get the feeling that everything is connected together, everything is interacting together, is alive. Anything I'm selecting in this worksheet, it has an effect in the next one. And here for this type of action, we mostly go with the select instead of the menu. It really makes sense to select something in this dashboard and to have immediate interactions in the next one. So as you can see, it's really easy, right? So now I want you to understand another type of interactivity. What can happen once I deselect what I have selected, or once I clear my selections? So we have selected show filtered values. So once I, for example, here click on the empty over here to deselect, nothing gonna change. So with that, we have kept the filtered values, and this is exactly what we have specified inside our action. But now if you say, you know what, once I deselect stuff in the source, I would like to have all the values as well deselected from the targets. In order to do that, we're gonna go back to our action, and we're gonna go and edit our filter action. So now if the users go and clear their selections or deselect, we want to show all the values for the target sheets. So let's switch it like this, click OK, Again, okay, and let's try this. So for example, I'm gonna go and select only the storage, and as you can see, we got only the storage. And once I clear my selections, once I deselect anything in the source, you can see we'll get all the values again in the target sheet. In this scenario, it makes more sense to use these options. If I'm not selecting anything from a source, nothing should be filtered in the targets. So now let's go and check the last option. Let's go to the worksheets, actions, and to the filters. Let's go and exclude all values. Let's select that. And let's try what can happen now. So now at the start, nothing happened. We see all the data from both sheets. So now let's go and select, for example, those subcategories. As usual, we will get all data filtered in the target sheets. But now once I deselect, everything gonna disappear from the target sheets. So that means the target sheet will only show the data if I select something in the source sheets. So that means nothing here is relevant as long as I'm not selecting anything in the source sheets. And once I start selecting something in the source sheets, the data gonna be shown. Otherwise, if I deselect it now, don't show anything. One more thing that I would like to show about the filter actions. If you go to the target sheets over here, you can see that we don't have any data, and Tableau gonna indicate that there is an action that is filtering the data inside these worksheets. And you can see in the name of the filter, we have the word action. Tableau wants to indicate that this filter is really depending on the actions from the users. So any value that is selected from the users, it's gonna impact this filter. So for example, if you go inside it and edit the filter, you can see nothing is selected, and that's because in our interactions, we didn't select anything here in the dashboards. And once, for example, I select those values, you can go back to the target sheet and you can see those values as well selected in the worksheets. And if you go inside the filter, you can see those values are as well selected inside the filter. So anything that starts with the action in the filter, this comes from an action filter, and the values inside it can be defined depending on the interactions that you have done. All right, so with that, we have covered everything for the filter actions in Tableau. Alright guys, now I would like to show you how to create quick actions in Tableau using the dashboards. For example, let's say that we have the sales and the profits and they are disconnected. There is no actions between them, but now I can go and create a filter actions between them very quickly. If you go, for example, to the sales over here, you can find a small icon for the filters. It says use as a filter. So if you click on that, you can see now it's filled. And now if I'm clicking on anything inside the sales, as you can see, the profit's gonna be filtered. And now if you go to the main menu, to the dashboard, to the actions, you can see that Tableau did create automatically new actions, and it's usually has the name of generated. So we have here filter 1 generated. This one is created automatically or quickly as we clicked in this small icon over here on the dashboard. And of course you can go over here and change the options. If you don't want to have select, you can move it to menu, to hover, and so on. And of course you can do the same thing for the profit insight. So let's go and close everything. Let's go to the profit insights and we can say, okay, the profit gonna filter as well the sales. So let's go click on that, and now let's deselect everything, and anything that I'm selecting in the profit, it's gonna as well filter the sales. So this is really nice and quick way in order to create actions in Tableau, but this is only for the type filter action. Alright guys, now we're going to talk about another type of actions. We have the highlight. The highlight is very similar to the filters, where the user is going to interact with the source sheets, and in the target sheet we're going to focus on a subset of data that we selected from the source. But the main difference here is that the unrelevant data will not be filtered out. All the data going to be exist in the target sheet, but only what we are selecting going to be highlighted in the target sheets. And the best way in order to understand the highlight action is to have a dashboard with 2 worksheets. So now let's go and create a highlight action. As usual, we're going to go to the main menu over here, but this time we're going to go to the dashboard. Then let's go to the actions and let's add a new action. So we're going to go over here, add an action, and then we're going to pick this time the highlight. As usual, we have to define the source, the trigger, and the target sheets. So let's go and give it a name. It's going to be highlight profit insight, and then the source is going to be our sales. So I'm just going to remove the profit from here, and the best way to work or to trigger a highlight is to have a hover. So I'm just going to run this action on the hover, and then the target going to be our profit insight. So I'm just going to remove the sales insights, and then here we have some options to define which fields going to be included in the interaction. As a default, it's going to be all the fields or dates and time. Then the last option, you have selected fields, so you can specify which field going to be included in the action. I'm gonna stay with the default all fields. So with that we have everything. Let's go and hit OK, and with that we got as well our action. Let's hit OK again. So now let's go and test the action. Let's go to the source sheet. The trigger gonna be mouse hover. So now as I'm mouse hovering on those informations, you can see that Tableau is reacting in the target sheet and focusing on the data that I'm like mouse hovering. So if I stay on the storage here with my mouse, you can see that Tableau is focusing on the storage in the target sheet, and you have like a highlighter with the yellow color. So as you can see, it's really nice, right? It adds like more interactivity, more dynamic to your views as the users are interacting with the worksheets. Another worksheet is getting highlighted, so it's really nice. And now you might say, you know what, I would like to have the same effect in the profit insights. So as I'm mouse hovering on those data, I would like to have highlights in the source, in the sales insights. So both of those reports or those worksheets can highlight each other's. In order to do that, it's really simple. Let's go to the main menu again, to the dashboards, actions, and let's go to the highlight action. And then let's include everything in the source sheets and as well everything in the target sheets. With that, all those worksheets can highlight each other's. So let's go and hit OK, and then again OK, and let's check. So now as you can see, as I'm mouse hovering on the profit insights, the highlight's going to be in the sales, and the vice versa. As I'm moving on the sales, you can see the highlight's going to be on the profits. So now the mouse hover gonna highlight both of the worksheets. Alright guys, so now generally speaking about the highlights in Tableau, there are different options where we can add highlights or control the highlight option. For example, if you go to the quick menu over here, you can see that we have an option to edit the highlights. So if you go over here, you can see that we can disable the highlights, we can enable it, we can define which fields gonna be included in the highlight. So for example, if I go over here and say, okay, disable workbook highlights, what's gonna happen is that the highlight action gonna be disabled. In order to enable it, we're gonna go again to the quick action over here and enable the workbook highlights. So as you can see now, I can highlight on those stuffs. And in Tableau, we can add highlights to the worksheets or to the dashboards. If you go to the main menu to the analyzes, and then here we have highlighters. If you go over here, we have the subcategory, since it is the only dimension that we have in these dashboards or on those worksheets. So let's go and click on that. Now, if you check the right side, we got something like a filter, but it's not really a filter, it is a highlighter. So if you click on this box over here, you will get a list of all distinct values inside the subcategory. So now what you can do, you can just mouse hover on those informations, and as you can see, the dashboard is going to be highlighted. So this is another way to trigger the action highlights inside your dashboards or worksheets by adding the highlighter on the right side. So for example, if I just go and click on that, it's going to stay highlighted whole time since we have selected this value over here. And of course, if you want to get everything back to the normal, you can go over here, click on the X and remove the value. With that, we got everything back without highlights. Alright guys, so that's all about highlights actions in Tableau. Alright guys, moving on to another type of actions, we have the sets. As we learned before previously in the sets, it can split your data into two groups, the in group and the out group. So now the one who is creating the dashboard or the worksheets gonna define which member is gonna be in and which member is gonna be out. But in order to make your visuals more interactive, we can give these options to the users so they can define which member is gonna be in and which member is gonna be out. And in order to do that, we're gonna go and create action sets. So first, let's create a view and a set. In order to do that, we're gonna stay with the big data source. Let's take the sales to the columns, the profit to the rows, and here in the middle we're gonna go and get the customer ID. So with that we got like data points, but we still don't have any sets. But first, let's go and make those points a little bit bigger in order to understand the members. And then I'm just gonna go and change the shape as well to be filled circles. So now that's it. Let's go now and create a set. In order to do that, I'm just gonna go and select those top right customers, and then we go over here and then we say create sets. Alright, I'm just gonna leave it as it is, and with that we got on the data pane a new dimensions for the sets. So now we're gonna go and add it to our view as a colors. So let's go and move it to the colors over here. So as you can see, the blue gonna be the in and the out's gonna be grayed out. I'm just gonna change those coloring. So let's go to the colors, and the in gonna be, let's say, the green, and the out gonna be the red. Let's go and hit apply and okay. And now as you can see, the one who's creating this view is deciding which members are in and which members are out. But now let's go and give these options to the users. In order to do that, we're going to go and create an action set. As usual, we're going to go to the main menu, to the worksheets. Let's go to actions and let's add a new action. This time we're going to use change set values. Let's go inside, and here we have the usual stuff. We have the source, what can I trigger the action, and the target. Let's first give it a name. So change customer ID set, and then we're going to go and define the source sheet. So it's going to be the action set that we have it, and then we have to define the action. I'm just going to leave it as select. The target going to be the target set. So in order to do that, we have to click over here, and then we will get here all the sets that we have inside our data source. In this example, we have only one set inside the big data source, so we have it over here, customer ID sets. So let's go and click on that, and now here we have more options about the sets. The left one going to be what can happen to the set once the users start interacting or selecting data points, and on the right side here we have options about what can happen once the users clear the selection, once the user deselects stuff in the visualizations. So now in order to understand those options, we have to play around with those values. So on the right side, I'm just going to say keep set values. So if I deselect anything in the view, nothing can happen. And now in this left group, we have assign values to set, add values to set, and remove values to set. We're going to start with the first one. So once the action is triggered, we're going to assign values to sets. What this means, if you choose this one, what Tableau going to do, going to empty the in group, and anything that you are selecting going to be the members of the in group. So let's see what this means. Let's go and hit OK, and then again OK. Again here we have to select in order to trigger the action, and as you can see we have those members are inside the group. So now let's say that I would like to select those 4 members over here. So once I start selecting those members, what can happen? Only those members going to be in the in group. So as you can see, those points are now out. So that means Tableau is removing everything and starting from scratch, and anything that you are selecting going to be the only members of the in group. So that's it for this option. The selection going to define the members of the in group. Let's go and change it to the second option. So let's go to our action, the change customer ID. So now let's move to this one. It says add values to sets. So what can happen this time? Tableau will not forget previously which members were inside the in group. Now we are just adding new members to the sets. So let's see how this works. Let's go and hit OK, and again OK. So now currently we have those 4 members in the group, and let's say that I would like to add 2 new members. So let's say that I would like to add those 2 members over here. So let's go and select them. So with that, you can see we still have those members in. We just have added 2 new members. So that's it. It's really simple, right? Let's go and try the last one. Let's go to the action and as well to the customer change ID. This one we're going to say remove values from sets. So now what can happen? It's going to be exactly like adding new members to the sets, but this time anything that you are selecting, it's going to remove those members from the sets. So let's go and try that out. Let's go and hit OK, and again OK. Let's say that I would like to remove this member from the in group and move it to the out group. In order to do that, let's go and just select it and click on it. So as you can see now, it's red and it is not anymore in the in group. So that's it. So this is about what can happen once we trigger the action. But now let's learn about what can happen once we start deselecting the action. So let's go to the actions over here and go back to our set action. So on the right side, we have here 3 options: keep set values, add all values to set, remove all values to sets. And so far we have always worked with the keep set values. So that means if you clear the selections, nothing gonna happen. The members that you have defined with your selections gonna stay in the group. But the other 2, it's gonna like destroy your definitions. So let's say that add all values to sets. So if you deselect, it's gonna add all values to the in group. So this option means if you deselect, everything gonna be in. And exactly the opposite, we have remove all values from sets. So if you deselect, everything gonna be out. So let's go and select this one, add all values to sets, and try this out. So now currently we have those 5 members in the group and the rest is out, and I'm like interacting with our report, and I select this point to be removed from the out group. So now once I deselect or clear my selection, what can happen? All the members gonna be in the group, and the other option gonna be exactly the opposite. If I deselect, everything gonna be red and gonna be out. All right, guys, so that's all for the set actions. As you can see, it's a really nice feature where you're gonna give the users the freedom to choose which member is gonna be in, which member is gonna be out, in order for them to do focus analysis instead of us, the one that is creating the dashboards. So it really adds more dynamic and more interactive to your views. Alright guys, now we're going to move to the last type of actions. We have the parameters. Again, here we can use actions in order to change the values of the parameters. So now let's have an example in order to understand how this works. Let's build now sales by month. So let's go and get the sales over here. And let's go and get the order date to the columns. I'm just going to change it to the months over here. And let's go and add the labels. So now what I would like to build in this view, as I'm like selecting data from the view, I would like to get the total sales of my selection. So whether I choose one point or I choose a different group of points, I would like to get the total sales of my selection. So now in order to do that, we're going to go and create another worksheet where we want to show the total sales of our selection. So let's go and create another worksheet. So the first thing that we have to do is to go and create a new parameter. Let's go to the data pane, to the empty space over here, right click on it and then create parameter. Let's give it a name. It's going to be the total sales. So inside this parameter, we're going to have the total sales of our selection. So we're going to have the data type float, the display format. Let's move it to a currency standard, and the current value can be, let's say, 0 instead of 1. So that's all. Let's go and hit OK. Right click on it, show parameter. Currently it's 0 and nothing in our view. So now I would like to have one sentence here that says total sales, and then we're going to have the value of the parameter. In order to do that, we have to go and create a new calculated field. So let's go over here in this arrow, create a new calculated field. So in order to do that, we're just going to go to our parameter from the data pane, drag and drop it to our calculations. So why we are doing this? Because we cannot use directly the parameter in our aggregations or in our view. So we always have to create a new calculated field, and inside it, we're going to have the value from the parameter. So that's all. Let's go and hit OK. So now on the left side, we have a new calculated field, our new measure. Let's go and put it inside the text over here. And as a default, we're going to have it as a sum. So as the user are selecting different points, we're going to have the sum of all our selections. So this aggregation is correct. But now here in the view, we have only 0, but I would like to have a sentence, total sales, then the value. So in order to do that, let's go to the text over here, then to the 3 points. And now we have a new window where we're going to customize the text. So we're going to say total sales, and then we have the value of our new calculated field, but let's just make everything bigger. So total sales, let's move it to 20, and the parameter or the calculated fields, it's going to be as well 20, and I would like to make it more bold. So that's all. Click OK. And as you can see now, we have total sales and the value is 0, which comes from the parameter. So now let's go and change this value to, for example, 100. Now, as you can see, we got the total sales of 100. And now I would like as well to change the format of the total sales. So let's go to our calculated field, right click on it, then let's go to format. And then here on the left side, we have numbers. So if you click on these options, we can go to the currency standards, and then let's move to United States. So it's going to be somewhere over here. So English, United States. And with that, we got the dollar sign. Alright guys, so now the next step is that I would like to bring everything in one dashboard, so both of the worksheets. Let's go and create a new dashboard. Let's get the total sales, and then we're gonna get the sales by month. So let me just make it a little bit bigger, and let's remove the title from the total sales. So now, as you can see, the total sales value comes from the parameter. So now, so far, everything is disconnected between those two worksheets. Anything that I'm selecting here, it will not be reflected inside the parameter. So now here comes the magic. I would like to change the value of the parameters depending on my actions or my interactions from this view. So in order to do that, as usual, we're going to go to the main menu over here to the dashboards. Then let's go to the actions, and then let's add a new action and choose this option, change parameter values. Let's go inside it. So here we have the usual stuff, the source, the trigger, and the targets. Let's give it a name, change parameter total sales. So let's define the source. It's going to be the sales by month. So let's just remove the sheet 7 from here. The sheet 7 is the total sales. And then the action going to be the select. So I would like to select and trigger the action. And then here we have to find our parameter. So we have only one. So the total sales, let's select that. So here on the right side, so what's going to happen once we clear our selections? So I would like to say, okay, let's set it to 0 if the users are not selecting anything. All right. So now with the last one, we have to define for Tableau, which field going to control the values of the parameters. By the sales by month, we have different informations. As you can see over here, we have the month and we have the sum of sales. Of course, the sum of sales is going to be controlling the values of the parameters. So let's go and select this value over here, and the aggregation going to be the sum since we are finding the total sales. So that's it all for now. Let's go and hit OK, then again OK. And now as you can see, we have the 100 value comes from the parameters. But if I select, for example, these data points over here, you can see that the total sales comes from my selection, the 64,000. So now if I go and select all those values from the view, Tableau gonna go and summarize all those sales from my selections and put it in the parameter value. So with that, we have like connection between the parameters and our actions to the view, which gives a lot of dynamic and interactivities to your dashboards. All right, guys, so that's all for the parameter actions. It's really nice feature in Tableau. Alright guys, now I would like to give you quick tips about when to use which type of triggers of actions. So for example, if you want to jump from your worksheet to another worksheet or to go to an external website, it's better to give the options to the users to select this option using menu. So first, show the menu, let the users see the link, and then if the users want to go there, they're gonna select the link and click on it. It's always better than to surprise them by select. If the users like select on something and like suddenly they go somewhere else, it's really not nice. So go with menu if you go to URL or go to sheet. And if you are using filter action, the best way is to use select. It's like more interactive. So once a user starts selecting from one worksheet, the other worksheet gonna be filtered. So I usually go with select if I'm using the filter actions, and Tableau used as well as a default if you are using a quick action. So for filter action, I usually go with select, and for the last one, the highlights, I really recommend you to go with the hover. So as the users are mouse hovering inside one worksheet, the other worksheet is as well interacting. It's really nice and more like modern. So really be careful about when and how to trigger which actions. Don't surprise your users by jumping somewhere else. If they are using like go to a URL and sheets, be careful, talk with your users about it, how they would like to see it, and then maybe together make a decisions about the interactivity and actions together with the users. Alright guys, so that's all for me about actions in Tableau. Alright, so that's all for the tips about the action triggers, and with that we have completed this section, the Tableau actions. And in the next section we're gonna cover a very important topic in Tableau, the Tableau calculations. We're gonna learn there how to manipulate the data in Tableau, and we're gonna learn many Tableau functions. Tableau calculations. We will cover now over 60 different functions in Tableau in order to manipulate your data. You will not only understand how to use all those Tableau functions, also you will understand the concept behind them using very simple sketches and examples in order for you to understand how those Tableau functions works, because some of those calculations are really complicated. So we will start first by covering the basics about Tableau calculations, and then we're gonna dive into the most used functions in the 4 categories: row level calculations, aggregate calculations, LOD expressions, and the table calculations. So let's start first by having an introduction to the basics of Tableau calculations. So now let's go. Alright everyone, so now we're gonna talk about the calculated fields in Tableau, and we're gonna start with the first question: why do we need calculated fields in the first place? As we learned before, as we are building our visualizations, we always go to the data pane, to the data source, and we grab those fields that we see to the view. So now let's imagine that you are in a scenario where you need extra informations that are not available in our data source, or you would like to manipulate and transform those informations to new informations, to new fields. Or let's say that we are building a very complex logic in our views. For all those scenarios, we can go and create new calculated fields in Tableau to be placed in our data source. So calculated fields in Tableau are user-defined fields that are created using formulas or expressions. So they are additional fields that you can create based on the original fields in the data source. Alright everyone, so now we're gonna move to the next question: how to create new calculated fields in Tableau. There are 5 methods on how to create calculated fields. 4 of them are globally. That means once you create the calculated fields, it's gonna appear on the data source, on the data pane, to be reused in any other worksheets or in any workbook that is connected to the data source. And we have one local method in order to create one calculated field only from one view, and we call it quick calculations. So now let's go and explore those 5 methods. So the first way to create a new calculated field, we can go to the data pane on the left side, right click on the white space. So right click over here, and the first option is create calculated field. So once we go over here, we get a new window where we're gonna write our expression. So that's it. This is the first way. Let's move to the next one. I'm just gonna close this. And if you go over here, we have a small arrow near the search. If you click on it, we will get exactly the same list. So as you can see, the first option, create calculated field. The third way, in order to do that, if you go to any of those fields inside our data source, let's say that we go to the addresses, right click on it, and then here we have the option of create, and the first one called create calculated field. So once you go there, we're gonna get exactly the same window, but this time we're gonna get the field name prepared in the expression. Because here we went specifically to the address and we create from there a new calculated field. So let's close this and I'm gonna show you the first method in order to create calculated field. We're gonna go to the Aliases in the menu over here, click on that, and here we have the option of create calculated field. So once we click on that, we're gonna get again the same window. So those are quickly the 4 methods on how to create a new calculated field. You will get always the same result. Only if you go to the field and you go from there and create calculated field, you will find the field name inside the expression. So now let's go and call it my first calculation. And I'm just gonna give anything here inside the expression. Let's just type 1. So let's go and hit OK. So now we can see on the data pane that Tableau did create for us a new field. So it is like a field like any other fields that we have on the data pane in our data source. It has as well a data type. It is continuous measure because I entered there 1, so it's like a number. So you can treat it exactly like any other fields. But here, to understand which fields are calculated and which fields are original, you can see on the icon over here, it has the equal sign. So that means if you see the equal sign near the data type icon in any field, that means this field is a calculated field. It is not original field that comes from the data source. Someone went and created this calculated field and it is based on the original data. So with that, you can quickly identify which fields are original data that comes from the source systems and which fields are calculated fields created from the users. So with that, we have created our first calculated field and it is a global field. That means if you go to any other worksheet, let's go for example to new one, we can find again our calculated field. So now let's move on to the next method where we're going to create a local calculated field relevant only for one view. So in order to do that, we're going to have first something on the view. Let's take for example the customer's first name and put it on the rows. Now in order to make quick calculated field locally for this view, we're gonna go inside the field, inside the dimension, and we can do that by double clicking. Once you do that, you can see we are now allowed to write something inside this field, and we are writing now the calculated field. Let's say that, okay, we have now capitalized letters of the first name and I would like to manipulate it and transform it to uppercase. So I would like to see everything as an uppercase. In order to do that, we have the function in Tableau called upper. So now I'm writing the function name and it's gonna transform the first name. So with that, I have created calculated field inside the first name. So once you go outside, like click somewhere outside or click enter. So now we can see on the results that this function did change the first name to uppercase. So with that, we have done a quick transformation, quick calculations inside the view. And if you grab the first name again from the data pane, you can see that nothing's changed. So we didn't change anything on the data source, we just change it quickly for this view. So this is how you can create quickly new calculated field in the view without affecting the data source, and it's going to be locally only available in this view. So now let's say that this transformation here is interesting and I would like to reuse it somewhere else in other views. So now in order to make it available in our data source, what we can do, we can grab this field from the visualizations and just put it on the data source. So let's release. So with this, you can see that Tableau added a new field inside the customers, and we know this is calculated field by checking the data type. You can see we have the equal sign. So Tableau offers us here to rename it. I would like to leave it as it is. And if you go inside it in order to edit the calculation, right click on it and edit the calculation, and again we got the window where we can configure the calculation. Alright guys, so with that I have showed you all the methods on how to create new calculated fields in Tableau. Alright, in the next step we're gonna go and learn the basic options that we have inside the calculated window. So let's go to our calculated field, my first calculation, and first let's show the value in the view. So let's drag it to the text over here, and as you can see we have the value number 1. So let's go and edit the calculated field in order to get the window. So right click on it and let's go to the edit. So what do we have over here? First we have the name of the calculated field, and we called it in this example my first calc, but of course you can go to the data pane or the data source and rename it directly directly from there, or you can do it inside the calculated window. Okay, the next information we have the name of the data source where we are creating the calculated field. In this example, we created the calculated field inside the small data source. This is really important if you have multiple data sources and you are creating a lot of calculated fields. It's really nice to know where I'm creating now this calculated field. So it's nice info. Now moving on to the most important section in this window, this white area where you can write your expression to define the calculated field. So currently we have one, but we can go and use different stuff. We can use the field names, parameters, functions, and so on. For example, we created last time the upper function for the first name. So with that, I have defined what should be done inside this calculated field. So this is my expression. And now don't worry about the syntaxes that I'm writing inside the expressions, because in the next tutorials, we're going to learn everything about the syntaxes, about different functions in Tableau. So don't worry about it now. Next information that we have is we have the info of the calculation is valid. So here Tableau gives us a quick information whether the expression that I just wrote is valid or invalid. So currently I wrote the calculation in a correct way. That's why we have everything fine from Tableau, but now let's make something wrong, and now we will get a red message from Tableau saying the calculation contains errors. And here we have small arrow. If you go over here, you will see the message. It says Tableau is expecting here a closing parenthesis. So here Tableau shows us a quick message to know what's wrong in our calculation. So if I go and add the parenthesis, you can see that the calculation is valid. So we have a quick info from Tableau. Moving on to the next information that we have in this window, it says one dependency and small arrow. So let's click on that and see what we have over here. It says changes to this calculation might change the following sheets. Sheet number 1. So here Tableau gives us a warning. Anything that you are changing in the expression inside this calculation, it might has an effect on the sheet number 1. And that's because we are using this calculated field in the view in the sheet number 1. So this is very important information, especially if you have different worksheets and you are using the same calculated field in different worksheets. And this happens a lot, especially if you are like focusing on the content of one view and you go and change the calculated field. So here it's like a reminder, a warning from Tableau tells you, all right, if you do this change, you can affect the following worksheets. So here my recommendation for you is always to go and check the dependencies to make sure that the changes that you are making currently to the calculated field, it is still relevant for the other sheets. Alright, so moving on, we have two simple buttons, the apply and OK. I don't have to talk about it, I think. Then we have here a small arrow, and this is very important. So let's go and click on that. What do we have here in this extension is documentations or a catalog of all functions that we have in Tableau. So for example, let's go and search for the function upper that we use in this example. So search for upper, and now we can see on the right side the documentation of this function. So here we have three informations from Tableau. The first one is the syntax of the function. So syntax says it starts with the upper keyword, then it accepts only field, and the data type should be a string. The next information we have a short description of the function. So it says it's gonna convert a text string to all uppercase letters. The third information, we have an example of use. So here it says, okay, if you have an upper for the value product, everything in lowercase, the output, the result gonna be a product in uppercase. So here we have a nice, short, quick descriptions about all functions that we have in Tableau, and this is very useful, especially while you are writing the calculations, because it doesn't make sense to memorize everything, right? I tend as well always to check whether I'm using the correct syntax or even I'm using the correct function. So I always check the examples and say, okay, this is the one that I need. And one more thing that we can see in this window, this drop-down menu, and here we have different groups of functions in Tableau. For example, we have here the group of string functions. If you go inside it, you will get the list of all functions that's going to manipulate the string fields. So we have here at the end, as you can see, the upper function that we use in our calculation. Alright guys, so with that we have covered all the options that you can see inside the window of calculated fields. Alright guys, so moving on, we're going to talk about the basic components of calculations in Tableau. So that means what kind of informations we can add inside the expressions, inside the calculations. The first thing that we can add inside the calculation is the comments. Comments are really useful for you and for the others to have some context or small descriptions why you are doing the calculation. So for example, in order to add comments to this code, we can go on the start and we have the forward 2 slashes. Then we can write anything. Anything after the forward 2 slashes will not be executed in the calculation. So for example, we can write here, calculation to change first name to upper case. So anything I'm writing over here will not be executed and as well will not be checked from Tableau. I really recommend always to add comments, so for you, if you visit this calculation later, you understand why you write this expression. Alright, moving on to the second information that we can add inside the calculations, that are the fields from the data source. So those are the orange colors. So we have it over here, the first name, but let's just remove everything and start from scratch. So if you want to add a new field inside this calculation field, you can start writing the field name. So as I'm writing now, Tableau gonna make a list of suggestions. So here Tableau defined three things. The first one is a function. As you can see, there is like a small icon like an F. This indicates that this is a function. Or the second information, it says the first name, and beside it there is a data type icon. This data type icon can indicate this is a field name. The third information is as well the first name with the icon, so that means it is a field, but here Tableau writes it, this is from the big data source because those two fields has the same name exactly. So here Tableau show for us that this field comes from different data source. The first one comes from the same data source, that's why Tableau don't have to like say, okay, it is from small data source because it is from the current one, but since the second one comes from different data source, Tableau indicates that this is a different field from different data source. So now since we want the first name from the current data source, we can go and select this one over here, and with that we have inserted a field inside our calculations, and as you can see it got the orange color. Another way to add fields inside our calculations, and that is by drag and drop. So let's say that I would like to get as well the last name, so I can go to the last name over here, drag and drop it inside the calculation, and as you can see with that we got our second field, and again it is the orange color. And of course the fields that we are add to calculations could be any fields. For example, let's go and add the sales. The sales is a measure, so we go to the orders and we have the sales. We can just drag and drop to the calculations. So as you can see, Tableau accept as well measures inside the calculations, and they're gonna have as well the same color, the orange color. Alright, moving on to the next and very important component, we have the Tableau functions. Tableau functions are built-in operators that could be used in order to manipulate, to transform, to change the content of one field. So for example, what we can do with the sales, we can go and calculate the total sales inside our data. So in order to do that, we can use the function sum. So before the field sales, we can start with the sum, and then we have the open the parentheses and then close it. So as you can see, this component, those functions in Tableau have always the color of light blue. So now what can happen, Tableau gonna go and summarize all the values inside the sales and present it as the result. So let's go and hit OK. We're gonna get an error here because we have changed the calculation. So let's go and remove it and let's get it again in the text. So with that we got the total sum of sales inside our data. So now let's go back to our calculated field and see the next component. We have the logical expressions. We can use the logical expressions in order to check whether a condition is true or false, and they have as well the color of black. So for example, let's say that we want to create the calculation where we are checking the sum of sales. If it is higher than 1000, then we want to see the value high at the end. So let me show you how we can do that. We're going to use the if statement. So it's going to start with the keyword if, and as you can see it is black because it is a logical expression. So if the sum of sales is higher than 1000, so we're going to use here the operator higher, greater than 1000. Then what's going to happen, we're going to have the value high, and then we're going to go and end the logical expression, and we can check over here that the calculation is valid. So here we have our logical expressions, if, then, and end. Don't worry about the syntax, we're going to learn everything in the next tutorials step by step with very simple examples. Alright, so now we're going to move to the last component that we can add to our calculations. We have the parameters. Parameters are like dynamic fields that we can add to visualizations in order to make everything dynamic in the views or in the calculations. Again, there will be a dedicated tutorial for that later. But now let's see how we can add a parameter field inside the calculation. So first we have to create quickly a parameter. In order to do that, I'm just going to close our calculation over here, and then we're going to go to the arrow in the data pane. Then we're going to have the create parameter. Click on that. Here we're going to get the window in order to configure the parameters. We're going to call it choose a number. So that's it. Let's close it and say OK. And now on the left side, we got a new parameter. Right click on it and show parameter. So with that, we got like on the right side an input field where you can add a value. For example, we have it now as a 1. We can add like 1000. So now nothing can happen in the view because we don't have anything, but we're gonna go and add this parameter inside the calculation. So let's go back to our calculation, my first calculation, right click on it, and then go and edit. And now what we're gonna do, instead of having 1000, we're gonna get the value from the parameter. So we make like a dynamic calculated field, so the user is gonna go and control this value. So let's go and remove the 1000s, and we're gonna start writing the name of the parameter like any other field. So it's gonna be choose, and we get it over here. So click on that, and with that we have added our parameter inside the calculation. And as you can see, parameters in Tableau has the color of purple. So that's it for the last component, and with that we have covered all different components that is possible to be used inside calculations. So now let's go and try the output. I'm gonna go and hit OK, and then I'm gonna remove this one, it's red. So let's get the products to the rows. So next we're gonna go and get our new calculated field. This time it's gonna be a dimension because the output of the calculated field gonna be a string value. So let's check the results, and as you can see over here we have 2 products with the value high, the rest gonna be null. So now let's go and get the sales in order to understand why those values are high, and that's because of our calculation. So anything above 1000 we're gonna get the value high, anything below it's gonna be null. And with the parameter the users are controlling the calculation. So if I go over here and say okay, instead of 1000s let's have 500. So with that we have included as well the other products, so all the products now has the high value in the calculated field. So with that we have generated new information to our visualizations. Alright guys, so now let's quickly summarize the components of the calculations. In this example, first we can see the comment. So this comment is gonna help us to document the purpose of the calculation, and it will not be executed. It's gonna be as well in the gray color. The next component we have the field. So any field inside our data source, whether it's dimension or measure, we can add it to our calculation. Like this one we have the sales, and they have the orange color. The next component we have the functions. They are the built-in operators in order to manipulate our data, and they have the blue color. The next components we have the operators. In this example we have 2 operators, the plus, the arithmetic operator, and as well the comparison operator. It is the higher than, and they're gonna have the black color. The next component is gonna be as well with the black color. We have the letter expressions. Those are static values that we can insert inside our calculations. It could be a number like here the 10, or it could be string like here the high. And here don't forget to add the double or single quotations marks in order for Tableau to understand this is a value, not a field or a parameter or function or anything else. And we can add as well date values. Alright, moving on to the next component, we have the logical expressions. We have if, then, and. They can help us in order to evaluate conditions inside Tableau and then to decide whether it's true or false. And the last component that we have inside the calculations, we have the parameters. They are the dynamic fields that we can use inside calculations. Alright, so that's all about the components of calculations. Alright, so now I'm going to talk about the nested calculations in Tableau. In Tableau, you can nest calculations by using the result of one calculations as an input for another calculation. And that's because sometimes you might be in a situation where we have complicated calculations with different steps. So for each step, we're going to have one calculation. So as you are implementing those steps, you're going to end up having multiple calculations, and they're going to be nested inside each other's. So now let me show you an example. Alright, so now we're going to go and create a new calculated field to manipulate the values of the field country to have a specific format. So in this example, let's take the first name of the customers and as well the countries. Now we're going to go and create a new field for the country with different format. So let's go and create a new calculated field, and then we're going to start with the first calculation where we're going to make all the letters of the field country with the uppercase. So we're going to have upper function, and then we're going to manipulate the field country. So we're going to start writing country, and here it is our field. So that's it for the first calculation. Let's go and hit OK. So with that, Tableau gonna go and create a new calculated field, new dimension inside our data source. So let's go and check the values. As you can see, all the letters, all the countries are with the uppercase. Alright, so now we're gonna move to the next step in the transformation, where we want to show only the first 3 characters of each values inside this new calculated field. So in order to do that, we're gonna go back to our calculated field and we're gonna edit it. And this time we're gonna use the function left. So you can go and search in the catalog to see the syntax of the left function. As you can see, it accepts two fields. The first one is going to be the string that we want to manipulate, and then we're going to have the number of characters that we want to show. So let me show you now step by step how we can do that. Let's go first to a new line. So we're going to have left, and then it needs two arguments, the field that we want to manipulate and the number of characters. The field that we want to manipulate is going to be the result of the upper function. So it's going to be this one over here. So I'm going to just cut it and insert it over here. So with that, we have the first argument. The second argument is going to be the number of characters that you want to show. It's going to be 3 characters. That's why we're going to specify 3. So this is how we can nest functions in Tableau. The first function to be executed is going to be the one inside. So the upper function going to be executed first, and then the result of this function going to be used as an input for the function outside, for the function left. So that means first we're going to go and make all the values inside the country as an uppercase. Then we're going to go and execute the left function where we're going to show only the first 3 characters. So now let's go and hit apply to check the results. With that, you can see we have now only 3 characters inside the values of the country. So again, the function inside going to be first executed, then the function outside. And with that, you can further expand this calculated field to more functions. For example, let's say the third step, we want to go and calculate the length of the characters. And in order to do that, we can use the len function. So we're going to add it at the start, and then the input of the field gonna be the output of those 2 functions. So as you can see, it's very easy to nest functions in Tableau. Let's go and hit apply and check the results. As you can see, everywhere we have the length of 3. So again, the order of execution gonna be the one just deep inside the upper function, then the left function, then the last one to be computed is the length function. So that's it. This is one method on how to create nested calculations in Tableau, but there is another method on how to do that. And that's by creating a second calculated field using the first calculated field. Let me show you what I mean. So we can go and close this one over here, and let's create a new calculated field. So we're going to call it second calculated field. So what we're going to do inside it is to use the output of the first calculated field. In this example, it is the country new. So this is our first calculated field, and then we're going to multiply it with 2, for example. So here again, the order of the computation going to be first Tableau has to calculate the first calculated field. So it's going to calculate the upper, left, and length, and then at the end it's going to come over here and multiply it with 2. So let's go and hit OK, and with that we got a new calculated field. Let's drag and drop it on the view. So as you can see, the result is going to have the value of 6. So when do I use the first method and when do I use the second method? Alright, so I'm going to show you how I usually decide on this. Let's go to our first calculation, and as you can see, those intermediate steps, if they are not important steps, like you don't want to use them in any other visualizations, then it doesn't make any sense to create for each intermediate steps a new field inside your data source. Then the data source can explode and you're going to have a lot of fields that are not necessary. So in this situation, I'm going to have all those intermediate steps in one calculations. But there are another scenario where you have a very complex calculation where the code going to be very huge and it's really hard to maintain everything in one calculations. So there I try to split it into steps, and each step gonna have like one field in the data source. And the last scenario where those intermediate steps are really important for something else, for different visualizations, or maybe as well for any other different calculations. And in order to not repeat myself and doing the same calculations over and over, I go and create a dedicated calculated field for each intermediate steps, only if they are important. Alright guys, so that's all for the nested calculations, and that was an introduction to calculations in Tableau. They are really important to make great visualizations, and don't worry, in the next videos we're gonna learn more and more about calculations in Tableau. In Tableau, we have many different functions that we can use inside the calculations. And in Tableau, we can categorize them into 4 different types of calculations. In this tutorial, we're going to talk about them. But first, we can have a very simple example to understand how they work and how they interact with each other. So let's go. Alright, so now let's say that we have the following product table inside our data source, where we have informations like the product, prices, quantities, and so on. Those data are the original data that we can find inside the data source. And now let's say that we need a new field inside our data source to show the data of the revenue. In order to do that, we can simply create a new calculated field where it's gonna multiply the prices with the quantities. So now with that, Tableau gonna go and create a new field inside our data source to store the result of of the calculations inside it. So Tableau gonna go row by multiplying the prices with the quantity. So for example, for the first row, it's gonna multiply 20 with 2, and Tableau gonna go and store it as a new field. Then Tableau gonna jump to the next row and do the same exact thing. So as you can see, Tableau is processing each rows individually and independently from each others. When the calculations is happening on one row, we don't care about the information that is present in the other rows. So Tableau gonna focus only on one row at a time. This type of calculations, we call it row level calculations, and the level of details we have it here is the lowest. So we have the level of detail from the data source. It's very important to understand that this type of calculations is the only type that will not go and aggregate the rows of the data source, and as well the only type that's gonna store the results at the data source. So that means Tableau will not go and calculate the result of these calculations each time you are using it in the visualizations. So it's gonna like pre-calculate it and store it in the data source, and the calculation will not be done on the fly. Alright, so now let's move to the visualizations, and let's say that I would like to show the total revenue of each product. And for that, we can use the function sum to summarize the values of the revenue, and we can go and add the dimension product to the view. And Tableau here gonna show only 3 rows in the view, a row for each product value. So that means we're gonna have P1, P2, and P3. Now this time Tableau will start summarizing and aggregating the rows in the data source, and that's gonna be at the level of the dimension. So for example, Tableau gonna start with the first product, the P1, and Tableau gonna summarize the first 2 rows from the data source. So we have 40 plus 60. Tableau gonna write at the output 100 directly in the visualization. Then it's gonna move to the next row. We have the P2. Here we have only 1 row at the data source, and the summarize of that's gonna be 20. And for the product 3, the P3, we have here 3 rows in the data source. So the summarization of 40 plus 25 plus 15, Tableau gonna have the answer 80 at the visualizations. So this time, as you can see, Tableau is not processing the rows of the data source one by one and individually. Instead, Tableau gonna go and summarize, group up the rows of the data source at the visualization level. This type of calculations, we call it aggregate calculations, and it's going to be calculated on the fly. That means the result of these functions and of those calculations will not be extra stored inside the data source. And now it's very important to understand the level of details of this new table that we have in the view. It has lower level of details as the data source, and the one who controls the level of details is the dimension that we have on the view. So the dimension that we use in the view gonna control the level of details for the aggregate calculations. And that's why we have another type of calculations because of that. Let's say that we have another scenario where you say, you know what, I would like to control the level of details. I want my calculations to show the total revenue of each category. So here we can use different functions like the fixed function. So we're gonna have fixed category and then sum the revenue. So that we are telling Tableau, okay, find the total revenue, but this time it's gonna be fixed, it's gonna be connected to the dimension category. So let me show you what's gonna happen. Tableau gonna go and check, okay, what is the category of P1? It is the category A. And now the next question, what is the total revenue of the category A? So here Tableau gonna summarize 40 plus 60 plus 20, and the result gonna be 120. And here Tableau will not show the total revenue of the product P1, but instead of that we are showing the total revenue of the category A. The same thing can happen for the next product. We have P2, it belongs to the same category, to A, so the total revenue of category A is again 120. And then the last product, P3, it belongs to a different category, this time to category P, and the total revenue of that's gonna be 40 plus 25 plus 15, the output gonna be 80 as the total revenue for the category B. So now who is controlling the aggregations? It's not anymore the dimension that we have on the view, but instead it's gonna be the dimension that we specify on the calculations. This type of calculations, we call it LOD expressions, level of details expressions. And here the same thing like the aggregations, it's gonna happen on the fly, nothing gonna be stored inside the data source. Alright, so now moving on to the last calculation type that we have in Tableau. Let's say that after I got the result in the view, I would like to calculate the rank of the products based on the data that is displayed in the view. And in order to do that, we can use the function rank of the summary of the revenue. So what can happen this time, Tableau will not go and query the data source. Instead of that, Tableau gonna go and query the visualization itself. So here it's like we are aggregating the aggregation. So based on the value that is displayed on the view, we can find that the product 1, pay 1, has the rank 1, then pay 2 has the rank 3, and pay 3 has the rank 2. This type of calculations, we call it table calculations, and it is unlike all other types. It is based on the context and on the data that is displayed on the view, and it will not go directly and query the data source. It is as well computed on the fly. That means the result will not be stored inside the data source. And if we are talking about the level of details, it depends as well on the visualization. So it's going to depend on the dimension products. Alright guys, so with that we have now a big picture about the 4 different types of calculations inside Tableau, and we can see how Tableau going to compute the calculations and present the data at the end in the results. Alright, so now we're going to start with the first type of calculations. We have the row level calculations, and here we have a lot of functions under this category if you compare it with the other types. So here we have the number functions, string, date, null, logical functions. There are a lot of functions, but we're going to cover them all in the next tutorials. So now let's go in Tableau and try a few of those calculations. Okay, so now back to Tableau, we're going to go to the small data source, and then we're going to go to the orders. As you can see, we have here the quantity and as well the unit price. Now we're going to go and calculate the revenue, where we're going to multiply the quantity with the unit price. In order to do that, we're going to create a new calculated fields in the data source, and this is going to be a row level calculations type. So let's go and create a new calculated field. So we're going to go to the data pane, right click on the empty space, create calculated field, and let's give it the name revenue, and then the formula for this is going to be quantity multiplied with the unit price. And now you might ask me, where do I find in Tableau all the functions that are related to the type row level calculations? Well, there is no specific place for that, but there's like orientations, right? So if you go to the documentation over here and check those groups, you will not find directly the types of the calculations, but you will find some groups that are similar to those types. For example, if you can see over here, we have the table calculations. If you go inside it, you're going to find all the functions that we could use in this type. And then we have another group called aggregate. And here you will not find only the aggregate calculations, but as well you will find the LOD expressions. And the last one, the last type, is the row level calculations, is actually the rest. So all other like the number, string, date, type conversions, all of those stuff are row level calculations. Alright, so now back to our calculations. Let's go over here and hit OK. And with that, you can see that Tableau did immediately create a new field in our data pane. And now, as I told you, if you are using row level calculations, Tableau gonna do the pre-calculations and store the results immediately in the data source. Let's go and check that. Either you can go to the data source page, or we can go to this small icon over here. It says view data. So let's go inside and check the results. Here we have to switch to the orders. And now let's scroll to the right. You can see we have the original field, we have the quantity, and as well the unit price. But we have as well our new calculated field, which is like any other field that we have in the data source. We have the revenue over here, and as you can see, Tableau did immediately store all the results of this calculated field in the data source, even though that we haven't created anything yet in the visualizations. So that means Tableau gonna prepare it for you in the data source, and we can check the results. For example, here we have the quantity 1, the unit price 215. We're gonna get the same, of course, and here the things are multiplied with 2. So as you can see, we are now multiplying the quantity with the unit price, and now we can see very clearly that the row level calculations will be calculated and performed on the row level individually and independently from each others. So the information that we have in the other rows will not affect the calculations of the first row. Alright guys, so that's it. This is how the row level calculations works in Tableau. Okay, so now we're gonna move to the next type of calculations. We have the aggregate calculations, and here we have few calculations. If you compare to the row level calculations, we have max, min, average, count, count distinct, sum, and attribute. Again, all of those gonna be covered in details in next tutorials, but now we're gonna go in Tableau and try a few of them. Alright everyone, so now we're gonna go and build a view where we have the total revenue by products. In order to do that, we're gonna go and get the product name from the small data source, and let's put it in the view. Now it's really important to understand the concepts. So now the product name is the dimension dimension that's going to define the level of details in these visualizations. So that means in this view, we have 5 rows, and this is completely controlled by the product name. So now I want you to understand how to pick which type of calculations we're going to use now to answer this question. We start always with the first question: do we have to aggregate the data? Since the task saying the total revenue, that means there is like an aggregation and summarizations. Well, that means we cannot use the row level calculations, then we have to use the other types for aggregations. Then we are left with the 3 types. Now the next question gonna be, do we have all the data in the view? Well, as you can see in our table, we have only the dimension informations. We don't have anything about the revenue. So that means no, we don't have all the data inside the view, and that's gonna means we will not use table calculations type, because the table calculations types always depend on the view. So if you don't have the data in the view, you cannot use table calculations. With that, we are left with 2 options. Either we can use the aggregate calculations or the LOD calculations. Well, the last question you're gonna ask, does the level of details that we have in the view gonna fulfill my requirements? Well, in this example, yes, because we want to have the total revenue by products. So we are talking about the products, and the dimension that we have inside the view exactly fulfill the level of details. So that means we can stay with the level of calculations that we have inside the view, and we don't need to use any LOD expressions. So if you follow those 3 simple questions, you can easily identify which type of calculations you need to solve your task. And in this example, it's going to be the aggregate calculations. So let's see how we can do that. And since the aggregate calculations are the default methods in Tableau in order to aggregate any data or any measure, it's going to be really easy to create. So all what we need is the revenue. So just drag and drop it here on top of those numbers. And with that, Tableau going to create immediately an aggregate calculations. We can see it over here, the sum of their revenue, and that's because it is the default methods on aggregating data. Tableau goes for each product inside the data and start aggregating all their revenues that are related to this product. And now the next step, what I usually do, I go and validate some examples. So I go and pick some of those products and start summarizing the values to check whether the value that I'm seeing in the visualizations is correct. Let's go and create a new sheet, and here we want to go to the lowest level. In order to do that, we're going to take the order ID, the view, and let's take now the product name. We can take the categories as well, and then let's take the revenue and put it on the APC over here. Let's make it a little bit bigger in order to see the names, and then we can go and sort the product names. So now we can go and pick any of those products in order to validate the answers. Let's take the LG Full HD monitor. As you can see, the total sum should be more than 3000. So let's go back to our aggregations and check the LG Full HD. You can see it is above the 3000. That means everything is fine, and with that we got the total revenue by products. And of course we have done this in the quick way where we drag and drop the field to the view, but if you want to do it as calculated field in order to reuse it later in different sheets, we can go and create new calculated fields. Let's call it total revenue, and then we're gonna have the same syntax, so the sum of revenue, and this time we're gonna use the nested calculations. So we have it already in another calculated field, so let's go and click on that, and as you can see the calculation is valid. Let's hit OK, and we got with that a new measure in our data pane. So if you go and replace it, you will get exact results. So as you can see in the result, nothing's changed. The only advantage to use this is to reuse it in different sheets and as well in different workbooks. Alright guys, so that's all for the aggregate calculations in Tableau. Alright guys, the third type of calculations in Tableau, we have the LOD calculations, or the level of details expressions. And here we have only 3 Tableau functions. We have the fixed, include, and exclude. So now let's go in Tableau and create one of those functions. Alright, so now we have the following task where we want to show the total revenue by category, but using the same view. So we're gonna stay with the same informations. We're gonna have the product name, we're gonna have the total revenue by the product, but I want to see side by side their total revenue by category. So let's go again through the 3 questions. The first questions, are we doing aggregations? Well, yes, that means we cannot use row level calculations. Then the next questions, are the data that we have in the view enough? Well, it's not. Here, it's not the total revenue by category, it's by the product. Well, that means we cannot use the table calculations. Now we come to the last question. Does the level of details in the view gonna support me to solve the task? Well, the answer is no. And that's because the level of details inside the view now defined by the product name, and it has higher level of details than the category. We want to have the total revenue by category. So the level of details that we have in the view will not support me. That's why I cannot use here aggregate calculations, and I have to go and use LOD expressions. So as you can see, very simple questions, and it's going to move you exactly to the right type of calculations in Tableau. And now you might say, wait. I can go and add the category informations to the view, and then I have the level of details of the category. Well, this will not work, and that's because the product name has a higher level of details. Let me show you what can happen if you bring the category. So let's go and grab the category to the right side over here. You can see nothing gonna change. We still are at the 5 rows, and that's because of the product name. Even if you move it to the left side over here, we don't have here 2 rows. We have here 5 rows. If you can check the details over here, we have 5 marks. So that's why even if you are adding the category, nothing gonna change. We are still with the product level of details. So now let's go and create a new calculated field to use the LOD expressions or calculations. So let's go to the left side and create a new calculated field. We can call it total revenue by category. And the syntax, don't worry about it. We're going to learn it in a separate tutorial about it. So it's going to have the following syntax: fixed. Then we have to specify the dimension that's going to control the level of details of the results. It's going to be the category. And then what we are doing, we are aggregating the revenue. So we have to add here sum of revenue, and then we have to close it. So that's it, the calculation is valid and everything is fine. Let's go and hit OK. So as usual, we're going to get a new calculated field in our data pane over here. So let's get the result and let's drag it over here to see the data. So we can see for each row, the total revenue by the category. So for the first one, it's going to be the total revenue by the accessories. The second one, the same because it belongs to the same category. The third one, the same. But the fourth one, you can see it belongs to a different category. And that's why we're going to get different numbers. So that's it. This is why we need LOD calculations in Tableau. Okay, so now we're going to move to the last type of calculations that we have, the table calculations. And here we have as well few calculations. So we have the running, window, rank, first, last, index, lookup, and so on. Again, here we're going to have dedicated tutorial for those stuff. But now let's go and try one of them. All right, everyone. So now we're going to move to the last task for this view. We want to show the running total of the revenue by the products. So here we're going to ask again the 3 questions. Are we aggregating? Well, yes, because we are having the running total of the revenue, so we cannot use the row level calculations. The next questions: are the data that we have in the visualizations are enough to solve this task? Well, yes. And that's because we have the total revenue by the products and the view, and based on those informations, we can build up the running total of the revenue by the product. So we have actually everything in the view in order to solve the tasks. And that's why we're going to go and use the type table calculations, and we will not bother with the third question, whether it's aggregated calculations or LOD, because it is table calculations. So let's go and create a new calculated field. We're going to call it running total revenue. So the syntax for that is as well very simple. We start with the running, then we have to select which aggregation type. It's going to be the sum. And then we have to go and specify which data going to be calculated inside this table calculations. And here we have only 2 informations. So either we're going to use the total revenue or the total revenue by category, the LOD, but we are talking about the total revenue by products. That's why we're going to include it over here. So it's going to be the sum of the revenue, and that's it. And the calculation is valid. So let's go and hit OK. And we're going to take our measure and put it as well in the view to check the results. So with that, we can see very nicely the running total of the revenue. It's very simple. It starts with the first value from the total revenue, then the next value going to be based on the previous value plus the total revenue. So those 2 values going to be added to each other in order to get this value. Then the next one the same, so the previous value plus the current total revenue. As you can see, we have nothing here. That's why we are getting the same value. So as you can see, as we are moving down, we are adding more total revenues to the total number. And now it's very important to understand that the table calculations are very sensitive to the data that is displayed in the view. So any change to this structure, we're going to get different numbers at the output. And this is not the case for the aggregate or the LOD calculations. Let me show you what I mean. For example, let's go and just change the sort of the data inside the product name. So let's go over here and make it descending. For example, you can see that the aggregate calculations or the LOD, the values are the same. It just changed the sort, but the values inside the table calculations did change completely because we have now different sort, and Tableau gonna recalculate the running total based on the view. So that means any interactions in the visualizations, it's gonna affect the table calculations functions, and it is completely based on the view. So that's it for now. This is about the table calculations in Tableau. Alright guys, so now we're going to talk about the order of computations of those different calculations types that we have in Tableau. So now let's say that we have the following calculations, and it's very similar to the nested calculations. Here we have different types. So we have the rank for the table calculations, we have the sum as an aggregate calculations, and we have the quantity multiplied with the price as a row level calculations. So the first thing to be executed is always the row level calculations. So the first one gonna be quantity multiplied with the price. Then the second type to be executed in Tableau gonna be the aggregate calculations. It's gonna be the sum function in Tableau. And the last type of calculations that's gonna be executed in Tableau gonna be the rank function, the table calculations. So again, row level calculations as a first, then the aggregate calculations, and always the last one, the table calculations. Okay, so now let's go and quickly recap how to choose the right calculation type. Here we have 3 questions. We start with the first one. Do you have the aggregated data? If no, then go and use the row level calculations. We are at the row level. If yes, then we jump to the next question. Is all the needed data already available in the visualizations? If yes, then we can use the table calculations. If no, then we have here the third question. Is the level of details in the visualizations matches the question or the requirements? If yes, then we can use the aggregate calculations. If no, we can go and use the LOD expressions or calculations. So if you follow my decision tree, you can simply find an answer for that. Alright guys, so with that you have now an overview of the different types of calculations that we have in Tableau. Next we're gonna do a deep dive in each type of them, and we will start with the row level calculations. Here we're gonna cover a lot of functions in Tableau that are very important to do data manipulations and transformations, and generate as well new informations that you need for your visualizations. Alright, so now we're gonna start with the first type of calculations, the row level calculations, and in this tutorial we're gonna cover the number functions in Tableau. So the main purpose of the number functions in Tableau is to manipulate and transform numerical values, so we can use them on any field with the data type number. And the most important use case for the number functions is to simplify the numbers. So here we have 3 functions. We have the ceiling, floor, and round in order to round the numbers to simpler form. And as usual, first let's understand the concept behind them, then we're gonna practice in Tableau. So let's go. Alright, so now let's say that we have the following scenario. We have built a view from the subcategories and the sum of sales. Now, if you take a look to those numbers, you can see that they are large numbers with a lot of fractions, a lot of details. We have 3 decimals over here. So those details are gonna make it really hard to read those numbers in the view. Instead of that, we can round those numbers to make it easier to read and hide those small details that are unnecessary here. So if you take the sales, the rounded sales, you can see now we have smaller size in the numbers, and we rounded all those fractions, all those decimal numbers. So with that, you can see if you compare the right to the left, it's easier to read, right? So now let's learn how this works. Each decimal number, like for example 1.4, it has always 2 integer neighbors. Think about it like we have a room. It has a ceiling and a floor. In this example, the 1.4 has the ceiling of 2 and the floor of 1. And here we might be in a situation where I don't want to deal with those details, with those fractions. I would like to have a whole number, a 2 or a 1. And here exactly we have 2 options. Either we're going to move it to the ceiling, to the higher number, or we're going to move it to the floor, to the lower number. So if you decide to use the ceiling function, the number going to be 2. So what we are doing here is we are rounding up the number to the higher value, to the ceiling. Or we are moving it to the floor, so that means we are rounding down the number. So the floor function gonna round down the 1.4 to 1. And now you might say, you know what, I don't want to decide whether it's gonna go to the ceiling or to the floor. I would like to have it automatic, so it should go to the nearest integer. And here we can use the round function. Let's have the following example. Let's say we are at 1.3. If you use round, we're gonna go to the nearest neighbor. The nearest neighbor gonna be the 1. So the round gonna move the value to 1. But now let's take another value, 1.7. So here the nearest neighbor is not the floor, it is the ceiling. So it's more near to 2. If you use the round function, it's gonna convert it to 2. And now let's say that our value is exactly in the middle, so 1.5. What can happen to the value if I use round? Because it has exactly the same distance to the ceiling and to the floor. And here what can happen is it's gonna be rounded up to the ceiling. We have to have only one value, so 1.5, the round of that's gonna be 2. So as you can see, this is how those three functions works. All we think about, it's like a room, you have a ceiling and floor. Alright, so now let's compare the three functions side by side. We're gonna start with the ceiling. So the ceiling gonna round up the numbers. The syntax in Tableau gonna look like this: ceiling, and it accepts only one argument, the original number. For example, the ceiling of 1.2 is gonna be 2, ceiling of 1.8 gonna be 2, ceiling of 1.5 gonna be 2. We are always going to the higher number. Let's move to the next one. It's gonna be exactly the opposite. So the floor gonna round down the numbers to a lower value. The syntax here is floor, it accepts as well only one number. The examples are floor 1.2 gonna be 1, 1.8 gonna be 1, and 1.5 gonna be as well 1. We are always going to the lower number. Now let's go to the last one. We have the round. It's gonna round the numbers to the nearest integer. The syntax for that gonna be a little bit different. We have round, then the original number, then we have a decimal. Here it's optional, of course. Here we can decide as well whether we're gonna see, for example, 1 decimal, 2 decimals, and if you leave it empty, it's gonna round it to a whole number. So now let's go to the examples for the same numbers. So if you round 1.2, it's gonna go to the floor. The nearest gonna be 1. If we round 1.8, the nearest gonna be the ceiling, so it's gonna go to the 2. And if we round 1.5, exactly the middle, it's gonna be rounded up to the ceiling, so we have a 2. So that's it. This is how the three functions work. Now let's go back to Tableau and start practicing. Alright guys, so back to Tableau. Let's create now a view that we're gonna show the orders with the sales. So we're gonna stay with the small data source. Let's take the order ID, put it on the rows, and let's grab the sales to the view. So as you can see, the sales don't have any fractions, and that's because not that the numbers are rounded, it's just the format is different. So in order to show the real values, we have to change the format. So in order to do that, we're gonna go to the measure sales over here, right click on it and go to the format. Then we're gonna go to the left side, we have here numbers. Let's click on this menu and go to the standard. So once you do that, you can see that we have the raw data as we have it in the data source. So now we want to round those numbers to make it similar to read in the view. In order to do that, we have the three functions, and we're gonna start with the ceiling. So let's close this over here and create a new calculated field. So right click over here in the white space, create calculated field. We're gonna call it sales ceiling. The syntax is really easy, so it starts with the ceiling keyword, and then inside it we have to have our field, the number. So our field is the sales, and as you can see, the calculations is valid. So let's hit OK. And as you can see, we have now the field, the new calculated field in the data source. So let's bring it to the view. Let's go and drag it over here. And as you can see, now we have our new field. Let me just make it a little bit bigger. And all those values are rounded. So let's take the first value. We have 215,88. As we are rounding up, we're going to go to the next higher value, which is 216. Everything is fine. Let's check this over here. So we have 56,11, and as we are rounding up, we're gonna go to the next integer, which is 57. So everything is fine, and the ceiling functions is now working. All right, so next we're gonna go and do exactly the opposite. We're gonna round down the numbers to the floor. So we're gonna go and create a new calculated field, and we're gonna call it sales floor. The syntax is as well really easy. The keyword is floor, and our value gonna be the sales. So that's it. The calculations is valid. Let's click OK. And our new field is already in our data source. Let's grab it to the view. So the first value was 215,88. As we are rounding down to the integer below it, it's gonna be 215. And this value over here, we have it 56,11. As we are going to the floor, it's gonna be 56. So everything is fine. And as you can see, it's exactly the opposite of the ceiling. Alright, so next we're gonna go and round the numbers automatically to the nearest neighbor using the round. So we're gonna go and create the third calculated field. We're gonna call it sales round. And the functions is really easy. So it starts with round, and it accepts two arguments. The first one is a must. It's going to be our number sales, and the second one going to be optional in case we want to decide on the number of decimals. So here we don't want to use it. We're going to leave it as default. We don't need any decimals or fractions. So we're going to leave it as like this. sales, and that's it. So as you can see, the calculation is valid, and we're gonna go and hit OK. Now our third calculated field as well in the data pane, let's just grab it to the view and check the values. So now the first value, 215,88, it is near to the ceiling, that's why the round gonna take it to 216. The next one we had 56,11, it's really near the floor, that's why Tableau or the round function gonna take it to 56. So as you can see, everything is fine and the numbers are moving to the nearest neighbor. Alright, so now let's say that we want to see the sales in our view, but having only one decimal, not two decimals like here in our example. So in order to do that, we can round those numbers to only one decimal using the round function. Let's go and create a new calculated field. Let's call it sales rounds 1, and we're gonna use as well the same keyword rounds. The number gonna be sales, and then we're gonna define how many decimals do we want. In this example, we want only one decimal, so we're gonna type here 1. So that's it. As you can see, the calculation is valid. Let's click OK. And here we have our new field. Let's bring it to the view. And now you might say, you know what, nothing's changed. We still have everything rounded to a whole number. There's no decimals. Well, that's about the format. So let's go and change that. We're gonna go over here, right click on it, and then let's go to format. And here we're gonna bring it to the standard. Once we do that, as you can see, now we have only one decimal value. We don't have two decimal values like the sales, like the original field in our data source. But now you might say, okay, maybe the round as well has decimals. So let's check the formats. We're gonna go to the round over here and let's click format. And now if we bring it to standard, as you can see, nothing is changing. So that means we don't have really no decimals. We have only a whole number. Alright, so now you might ask me, when do I use ceiling and when do I use floor? Well, there is no rule for that. It really depends on the use case and on the requirement. For example, if I'm building a dashboard for budgeting, to plan a budget, I would go always with the ceiling to make sure that I'm not forgetting anything and I'm not short in the budget at the end. So in this use case, I tend always to use ceiling and never use floor or round. It really depends on the requirement and the use case. So as you can see, those three functions really makes the visualizations easier to read and more simpler. Alright everyone, so far we have learned how to simplify the numbers in Tableau using the three number functions, ceiling, floor, and round. And that's it for the first group, the number functions. Next we can learn the string functions in Tableau. Alright, so now we're going to focus on the second group of functions in Tableau under the category row-level calculations. We have the string functions. And the main purpose of the string functions in Tableau is to manipulate and transform the text values. So any field in our dataset with the data type string. There are many use cases and reasons to use string functions in Tableau. For example, we can use it to clean up our data and bring our text to standard cases. For example, we can change the case to either lower or upper. And the next use case as well is about to clean up our data in Tableau by removing any unwanted spaces. So here we have three functions, the left trim, right trim, and trim. Moving on to the next group or use case, we have here three functions to extract specific substring from a text. So we have left, right, and mid. The next use case is to search for specific patterns. And here we have five functions: start with, end with, contains, find, and find nth. Then we have another use case for the string functions to combine and split data inside Tableau. So here we have the concat operator and as well split function. And the last use case is to replace specific substring with another substring. So here we have the function replace. So as you can see, we have a lot of string functions and tools to manipulate, transform, clean up the text values in Tableau. And now we're gonna start with the first use case about the string functions, how to clean up our data and bring our text to standard case using the two functions lower and upper. But as usual, first we have to understand the concept before we start practicing in Tableau. So let's go. Alright, so now let's go and check the following data quality issue in our view. If you check the dimension products over here, we have three values for the same word. So we have keyboard, 3 times in the view, which is really wrong. And that's because the data quality from the source system where we get the data from is simply low. This happens if you have like a lot of people working in a big project and you have a lot of products, so they may enter like different names for the same products. So here we have a case issue in the product name. And what I usually do in my projects, I go and contact the source systems and tell them about the data quality issues that they have. But sometimes it might take a long time until they fix it. So in the visualizations, we can go and fix and clean up those stuff. And in Tableau, we have a lot of tools and functions to manipulate and clean up the dimensions. So for example, we can use the upper or the lower functions in order to bring standards to the values. So if we go and use the lower, we can have the following results. So we can have in this example only 3 products in the visualizations, and all those 3 values can be aggregated for the quantity in only 1 row, which is really correct. So now if you compare the first view with the second view, you can see that we have improved the data quality in the visualizations. So now let's go and understand how those 2 functions works. Now let's have the following example about the customer's name. The names could be written like this. The first character of the first name and the last name is capitalized, or everything as an uppercase, or the opposite where we have everything in lowercase. So as you can see, we can write the customer's name in different cases. Now in Tableau, we have to bring those names in standards, and we have 2 ways to do that. Either we bring everything to lowercase or to uppercase. And now if you decided to go with the uppercase for the customer's name, what can happen? The first customer can be converted completely to uppercase. The second customer is already an uppercase, so nothing can happen. It's going to stay the same. The third one, it is lowercase, so it can be converted to uppercase. But now if you want to go with the lower name for the customers, this is what's going to happen. The first customer can be converted to a lowercase. The second one as well can be converted from upper to lower. The third one, nothing can happen because it's already lowercase. So as you can see, with this function, we are forcing the names to be either upper or lower, so we bring standards to the visualizations. Now we're gonna go and compare those 2 functions together. We start with the upper. It's gonna convert the characters to uppercase. The syntax in Tableau gonna be the following. It starts with the keyword upper. It accepts only 1 field, the string. The output gonna be as well string. For example, if we take upper Maria, the first character is capitalized. The output gonna be string Maria in uppercase. So now let's go to the lower. It's gonna be exactly the opposite. So it's gonna convert the characters to lowercase. The syntax gonna be similar to here. So we have lower, then 1 field the string. The output can be as well a string. The example here is lower Maria. So Maria can be in the output as lowercase. So those 2 functions are simple and easy to use, but still they are very important. I tend to use them a lot in my projects to clean up the data. So now let's go back in Tableau and start practicing. Alright, for those 2 functions, I have prepared an extra file with the low data quality in the product names. So in order to connect this file, we have to create a new data source. So let's go to the data source page over here, and then we're gonna go and create a new data source. Then we're gonna go to the text file. You can find it inside the small folder. So we have here a CSV file called products low quality. Let's go and connect it. It's only 1 table, and if you check the data grid over here, you can see we have problems in the product 1. So you can see we have here keyboard in uppercase, keyboard in lowercase, or with the first character capitalized. So now let's go back to our sheet and start checking the data as well from there. And now let's go to the data pane. Make sure we are selecting the new data source. We have here a product 1. Here we have the case issue. So let's bring it in the view and check the values. As you can see, we can find like 5 products, but in reality we have only 3, right? So here we have the keyboard 3 times, monitor and mouse. We should have only 3 keyboard, monitor and mouse. So we have a data quality issue in the product names. And Tableau is case sensitive, so it can present the data exactly as it is from the source system. Let's take the quantity and put it in the columns, and as you can see, those 3 values will not be aggregated together since Tableau gonna think those are 3 different products. Let's show the values here in the labels. Let's take it to the color as well. So now we're gonna go and clean up the data using the lower function. In order to do that, we have to create a new calculated field. So let's go to the data pane over here, right click on the empty space, create calculated field. We're gonna call it products lower. So it starts with the keyword lower, and it accepts only 1 value, the string. So we're gonna have the products 1. And that's it. So as you can see, the calculation is valid and the output gonna be a string, the product. So let's go and hit OK. And now if you check the data pane, we have here our new dimension, the calculated field. Let's bring it to the view in the rows to start comparing the values. The first one, as you can see, it is an uppercase. So the output gonna be a lowercase of the keyboard. The next one is already lowercase, so nothing gonna change. The third one is completely uppercase. from the original data, but the output is lowercase. So as you can see, we have all the names here in lowercase. Now, if you go and remove the product one over here, you can see we're going to end up having only 3 values, only 3 products, which is correct. So with that, we have cleaned up the data using the lowercase. So now let's go and clean up the data, this time using the upper function. We're going to do the same. We're going to go and create a new calculated field. Let's call it products upper. So we're going to use the function upper over here, and it accepts only one field, our products. So products 1, and that's it. So the calculation is valid. Let's click OK. And now if you check the data pane, we have a new calculated field, new dimension. So let's bring it to the view and start comparing the values. I'm going to bring as well the original field. So the first one is capitalized. As you can see, the output going to be an uppercase. The second one is completely lowercase, going to be as well completely uppercase. The third one, nothing going to change. So as you can see, all the values now in uppercase. So now I'm going to go and remove the others to see the final results. As you can see, we have only 3 products in the visualization, which is really correct. And with that, we have fixed the data quality using the uppercase. Alright, so now you might ask me, should I use a lowercase or uppercase in my views? Well, if you're asking an IT guy like me, I'm gonna answer like this. It depends. It depends on the fields that you are using in the views. Let's have the following example. So here we have 2 views, the left one with the lowercase and the product's name, and the second one is with the uppercase. So if you take a look now to those 2 views, what do you think it is easier to read? Well, if you have a normal text or a long text like the product's name, the customer's name, and so on, it's always better to use a lowercase. The lowercase are like easier to read compared to the uppercase. The uppercase is going to take as well more space, it's more aggressive, and it's really hard to read. So for this scenario, I would go and recommend you to use the lowercase. In modern design, they tend to use lowercase since it's provide more slick and minimalist look in the website and in the look and feeling for the visualizations. So the lowercase is easier to read, it's more modern. If you compare it to the uppercase, it's hard to read and it's like someone is shouting. Let's take now another example. We have here an aggregations for the country abbreviation. So here we have it as a lowercase and as well as the uppercase. This time, if you compare them together, you can see that maybe it's more better to use the uppercase, and that's because since it's very short, the abbreviations has maximum maybe 3 characters, it's really hard to see in the visualizations. They are really small, so if you have it like a big characters, it's easier to read. So with the abbreviations, I always tend to use the uppercase. So the abbreviations, if they are written in uppercase, they're gonna bring standards and they're gonna avoid misinterpretations of the data. So if you look to the right side over here, you can understand immediately, okay, here we are talking about countries. But if you are on the left side, you might get confused. For example, are we talking about USA or the word us? The same goes for Italy. Is it like the it that we use it in sentences in the pronoun, or is it like the abbreviation of Italy? So here, if you write it in lowercase, you might introduce some misunderstanding and misinterpretations. So for the abbreviations, I always tend to use uppercase. It's more clear and easy to read for short names. So that's why the answers that comes from the IT, it depends. It depends on the use case, the requirements, and so on. So sometimes we go with the lower, sometimes we go with the upper, but 90% I go with the lowercase for the names and so on, but only for the abbreviations, I go with the upper. So with that, you have at least some orientations in your visualization. Alright, so that's all about how to clean up the data by bringing our text to standard case using the 2 functions, lower and upper. Next, we're going to start talking about the 3 functions, left trim, right trim, and trim. Alright, so now we're going to talk about another string functions in Tableau to clean up our data by removing unwanted spaces using the 3 functions, left trim, right trim, and trim. And of course, as usual, we have to understand first the concept behind them, and then we're going to practice in Tableau. So let's go. Alright, so now we have the following scenario where we have again a bad data quality in our view. If you check the products, we can see that we have 4 times the keyboard. So what is going on? We have here no case issue. Like all of them are capitalized in the first character, so there is no lowercase, uppercase, everything is fine. Why Tableau didn't aggregate all those values in one row, in one product? Because here we have only 3 products. So what is going on here? What happened? Well, we have the dirty spaces in the product name. In the keyboard, there are like unwanted spaces. It's really hard to see in the visual. You can see that like everything looks fine, right? But there are spaces inside the keyboard and we have to remove it. So now in order to clean up the data and remove those dirty spaces, we can use one of the three functions: left trim, right trim, or trim. And if we apply those functions on the product name, we're gonna get the result like this. Only 3 products and everything gonna be fine. So let's understand how those functions works. So let's have the following simple examples. Let's say that we have the word monitor, but on the left side we have a white space. In order to remove it, we can use the Tableau function left trim. So left trim gonna remove any unwanted spaces from the left side of the word. And now we might have the opposite situation where we have the monitor, but on the right side there is a white space. In order to remove those spaces, we can use the function in Tableau right trim. So right trim gonna remove any spaces from the right side of the word. Moving on to the third scenario, we have the same word monitor, but this time on the left and on the right there are white spaces. So in order to remove those spaces, either we're gonna use both of the functions left trim and right trim, or we can use the third function, a trim. If you use the trim function in Tableau for this scenario, it's gonna remove all the white spaces from the left side and as well all the white spaces from the right side. Alright, so now we're gonna go quickly compare those 3 functions. The left trim gonna remove any leading spaces, the right trim gonna remove any trailing spaces, and the trim can remove both of them, the leading and trailing spaces. And the syntaxes in Tableau are really simple. So for example, we have here the left trim keyword, then it accepts only one string field. The output gonna be a string value. So for example, let's say we want to left trim this value. We have Maria on the left side, we have a white space, and as well on the right side. So if you use a left trim, it's gonna remove only the leading spaces. So it's gonna just remove the space from the left and gonna leave the space that we have on the right, because it's only left trimming. Let's go to the next one. It's exactly the opposite, but the syntax is almost the same. So we have a right trim, it accepts the field string, the output gonna be as well a string value. So if we stay with the same example, it's gonna remove only the trailing space. So the space on the left side gonna stay in this example. Now let's move to the last one. I think you already got it. We're gonna use only the trim here, not left or right, so both of them, and it accepts as well a string field. The output gonna be a string value, and the example gonna be the following. So Maria with the left and right spaces, what's gonna happen, we're gonna remove the left space and as well the right space. So those functions are really easy to use and very important to improve your data quality in the visualizations. Let's go back to Tableau and start practicing. Okay, first make sure to select the right data source. So we're gonna stay with the products low quality since I prepared there the examples, and now we're gonna go with the product 2. So just drag and drop it here in the view, and as you can see we have now 4 products for the keyboard. Now it's really hard to see where are those white spaces. For the first 2 you can see they are like little bit shifted to the right, but for the second 2 keyboards we are not sure whether they are like on the right side a white space or not. And the situation is going to be really bad if we switch to different visualizations. So let's take the quantity, and now in the bar diagram it's almost impossible to see whether there are like any white spaces. So if I'm facing this situation in my projects, I go first and start counting how many characters do I have in each product. So I calculate the length of each word. So in order to do that, we're going to create a new calculated field. Let's go and create a new one, and we're going to call it products length. So the keyword for that to calculate the length is len, and that's it. And then it accepts only one field, string field, and the output gonna be a number. So our field gonna be the product 2. Make sure to select the correct one, and that's it. The calculation is valid. Let's click OK. And since the output gonna be a number, Tableau gonna go and create a continuous measure. So I'm just gonna remove the quantity from the view, and let's bring our new calculated field to the view. So the length of the first one has a 9, so this means we have only one white space. The second one has 2 white spaces, the third one is correct, the first one is as well, has a 1 white space. So with the length function, we can easily detect whether there are dirty spaces in our words. So now in order to remove and clean up those problems, we're gonna use the trim functions. So let's start with the left trim, and we're gonna go and create a new calculated field. So let's go and do that. We're gonna call it products left trim, and we're gonna start with the syntax left trim, and it accepts only one string field. it's gonna be the product 2. Make sure to select the correct one, and the calculation is valid. Let's go and hit OK. And now we notice that Tableau created a new dimension because the output is a string. Let's go and put it here in the view. So now what's gonna happen to the values inside the products? All the spaces from the left side gonna be removed or trimmed. But again, here it's really hard to see from the view whether everything is fine. So we're gonna go again and calculate the length of the new field. So let's go and change the calculations inside our calculated field. So instead of having the product 2, we're gonna remove it and insert the new dimension. Let's click OK. Alright, so now let's check the result. As you can see, we have some values fixed. So the first one, we have it as 8. The second one, we still have a space. The third one is anyway correct. The third one is as well incorrect. So as you can see, the situation is now a little bit better, but we still have spaces. That means we have spaces on the right side. So in order to fix this, we're gonna go and trim from the right side. So let's go back to our calculations, the left trim. Let's edit it and add the right trim. So we're gonna go over here. We're gonna have nested calculations. So right trim, and we want the result from the left trim. So let's go and hit OK, but maybe I'm gonna change the name to trim. So let's hit OK. So what can happen to the values inside the product? We are trimming everything from the left and as well from the right. And as you can see now, the length is as well correct. So all those values has the length of 8. So in order to test this as well, we're gonna remove the product 2 from the view. And we have here only 3 values. And of course, the links doesn't make any sense here because we are summarizing the links of all the products inside the orders. So instead of having it as a measure, maybe we can convert it to dimensions to not have any calculations. So I'm just going to remove it from here and just add the product length. And as you can see, everything is fine. And now, of course, for this scenario, we have an easier solution. We can just use a trim instead of using left and right trim in one calculation. So let's go and do that. So we're going to go back to our calculation and edit it. So we're just gonna remove everything. We're gonna use the keyword trim, and then it accepts only one field. It's gonna be the product 2. And as you can see, the calculation is valid. Let's click OK. So as you can see, nothing gonna change in the view. We're gonna get exactly the same results. So with that, we have cleaned up the values inside the products by removing any dirty or unwanted spaces. Alright, I want to show you one more method on how to detect whether there is like bad quality in your data by having unwanted spaces, and that's especially if you have a big data source. If you have a lot of values, it's really hard to detect those stuff if you are using the links function. So I'm going to show you now how I usually do it if I have a big data source. So what I usually do if I have suspicion about one field where I think the users are like manually entering the values, is that I go and count the distance value inside this field. So now let me show you how I usually do it. Let's go and create a new calculated field, and we're gonna call it products count D. So the syntax for that is gonna be count and then the word D. We are counting the distance value inside our products. The field gonna be product 2. The output for that is going to be a number, so the calculation is valid. Let's go and hit OK. So as you can see on the left side, we have a new continuous measure. It's going to count how many distinct values we have inside the products. So let's see the results. I'm just going to go and remove everything from the view. I'm going to take the count D and put it in the text. So now the result's going to say I have 6 different products inside my data source, but I have suspicions about it. So now what I'm gonna do, I'm gonna go and start trimming the values inside the products, and my expectation gonna be the following. If the number gonna stay the same, then we don't have any spaces. But if the number gonna go smaller, then we have unwanted spaces inside the products. So let's start testing that. We're gonna go to our calculation and start adding our trims. We start always with the left trim or right trim. Why we don't go immediately to the trim? Because if you are trimming everything from the left and the right, this can has a bad performance in Tableau because it needs resources. So if you are only left trimming or only right trimming, it's going to be easier for Tableau to do it. But if you always go immediately to the trim, you might have bad performance. So that's why I always start with the left trim. So let's go to the left trim and check the results. So I'm just gonna add it to the product over here. So with that, we are first left trimming the product 2, then we are counting how many distinct values we're gonna see inside this database. The calculation is valid. Let's hit OK. Alright, so now we moved from 6 to 4 products. This is alerting for me. That means there is like leading spaces. So now the next step, what I usually do is to go and test whether we have any right spaces on the right side. For that, either I'm gonna add a right trim, or I'm just simply gonna use use the trim. So now if we add the right trim and the number gonna stay the same 4, that means we have only problem with the left spaces. But if the number gonna go smaller, that means we have as well right spaces. So now what we're gonna do, we're gonna go again to our measure and edit the calculation. And instead of having left trim, I'm just gonna have now trim to test as well the right spaces. So let's go and hit OK. Now as you can see, we went from 4 to 3. That means we have as well right spaces, not only left but as well right. So the total number of products went from 6 to 4 to 3. So this is how I usually do it to decide whether I'm gonna use only left trim or right trim or both of them instead of using immediate trim. I saw a lot of projects and a lot of developers tend to like overreact with this. So if they see like a string value, they go immediately and trim it just in order to have a correct result at the Tableau visualization. But believe me, if you do this always, you're gonna have bad reaction in Tableau and you're gonna have bad performance. So take little time investigating whether it's really necessary or not. Alright, so that's all about how to clean up our data by removing unwanted spaces using the 3 functions: left trim, right trim, and trim. Next, we're gonna talk about another group, the left, right, and mid. Okay, so now we're gonna cover another group of string functions in Tableau to extract specific substring from the text using the 3 functions left, right, and mid. And as usual, let's understand the concept, then we're gonna practice in Tableau. Let's go. Alright everyone, so in real scenarios, in real life projects, the data that comes from the source systems usually are way more complicated than the data that you can find in samples, tutorials, courses, and so on, because the processes in real projects are way more complicated. So the example that we can see here could be the product name inside your project. So here you can see we have a lot of informations in only one field. For example, we have the canon, this could be the product name, the next one we have the product ID, and the third one is the product code. All those informations, we might find it underneath the product name in only one field. So in the visualizations, we might be interested in only one piece of information, not the whole thing. So we could be interested in only the canon, the product name, or we need only the ID, so 789, or we want only the code to be in the visualizations. So we need in Tableau such a function or tools in order to extract those pieces of informations and split the one field to 3 fields. And in Tableau, there are a lot of functions and ways in order to achieve this goal. One of them is to use the functions left, right, and mid in order to cut this field into multiple fields. So we're gonna start now with the first one. Let's understand the left. The first thing to understand is that each character in our string has a position number. For example, we have the C, it has the position number 1, the A, 2, and 3, and so on until we reach the last character 5, it has the position 14. So we are counting from the left until we go to the right. And now in this example, we are interested only on the product name. So we're gonna focus only on this one. And as you can see, it ends with the position 5. So the syntax in Tableau in order to do the left is the following. It starts with the left, then it needs 2 arguments. The first one is the field itself, so the string itself, then the numbers of characters that we want to keep, and the output, the result gonna be a string value. So for example, we're gonna take left, then our value, and the number of characters gonna be 5. So we are keeping 5 characters from the left side. So let's see how this is gonna work. So we're gonna start counting from the left and we move to the right. So the starting character is C, so we start counting 1, 2, 3, 4, 5, and this is exactly the number of characters, and we make a cut here. Anything after the 5 or after n gonna be removed, and we keep here only 5 characters. We're gonna have the output of canon. So in this example, we are cutting all the values after the character with the position number 5. Alright, so this is how the left function works in Tableau. Let's move on to the next function. It's exactly the opposite. We're gonna have the right function. Let's say that we are not anymore interested in the product name. We would like to have and extract the product code, the last 4 characters of our string. And now if you are considering to use the right function, what's gonna happen? The position number of the characters gonna be exactly the opposite. We're gonna start counting from the right side as we are moving to the left. So the first character gonna be the character 5, the second one R, the third E, and the last character, number 14, gonna be the C. So now we want to focus on the product code and we're gonna use the right function. The syntax for the right function is very similar to the left, so it starts with the right keyword, then we need our field, the string field, then the number of characters, the output gonna be as well a string value. So this time gonna be the example like this. It's gonna have right, our string, then the number of characters that we want to keep from the right side is 4. Let's see how this is gonna work. So the right function gonna start counting from the right side and we move on to the left. So we start counting from here, 1, 2, 3, 4, and that's it. Here we make cut. And all the characters after the position number 4 will be ignored, will not be part of the results. So at the end, we're gonna get only 4 characters from the right side, CER5. So this is how the right functions works in Tableau. We start counting from the right side and we keep only, like for example here, 4 characters. Alright, so now we're gonna move to the third one. We have the mid function. Alright, so now we want to extract the last piece of information that we have in our string, the product ID, the one in the middle. So we are not interested in the first part, the product name, or the last part, the code. We want to get exactly this information in the middle. If you are using mid, we're gonna count from left to right, exactly like the left function. So the first character gonna be the C and the last character gonna be the 5. The syntax in Tableau is slightly different as left and right. So we start with mid, then we have 3 arguments. The first one, as usual, the string value that we want to manipulate. The next one here is new. We can define the start point where we're gonna start counting how many characters we're gonna leave. Then we have the length. Here it's like the number of characters, but this time it is optional. So if you leave it, we're gonna consider everything after the start point, or if you specify it, we're gonna have exactly the same number of characters that you define. The output gonna be here as well, a string value. So let's take here an example. We're gonna have mid, then our value. We want to start counting from 7, and we want to keep only 3 characters in the output. Okay, so now let's see how this is gonna work. The start position to count the number is the position number 7. So we're gonna start from this value and we're gonna count 3 characters. So 1, 2, 3, and cut. So now what we are doing, we are cutting 2 things, the starting position and the end position. That means all the characters before the starting point will be ignored, will not be at the results, and as well all the characters after the final one at the cut will be ignored. So the output gonna be 7, 8, 9. So with that, we extracted an information in the middle of our string. So this is how the mid function work. So as you can see, with those 3 functions, with those 3 tools in Tableau, we can cut anything in our string and generate new data. So now let's go in Tableau and start practicing. There are many use cases for those 3 functions. For example, let's start working with the URL. The URL has usually a structure and we want to extract part of the informations inside each URL. In our data sources, we have a URL in the images. So if you go to the small data source, go to the products, and here we have the product image. Let's drag and drop it on the rows and check the structure. So the standard URLs usually start with the protocol, then we have a domain, and then at the end we have like a file or something. Our files here are all images, like we practice in the image role. So now the first task is to extract only the protocols from our URL. Now as the protocols are from the left side, I think you know already that we want to use the left function. So we can go and count how many characters we want to leave. So we need 5 characters. Let's go and create a new calculated field because we need a new field. We're gonna call it URL, and then we're gonna have the protocol. So it starts like this, the left, and then it needs 2 arguments. So the data that we need is product image. We have it over here, and we want to cut 5 characters. So comma, we're gonna specify here 5. So as you can see, the calculation is valid. Let's go and try that out. We're gonna go and hit OK. And as you can see on the left side, we have our new dimension, our new calculated field. Let's go and bring it to the view. So drag and drop it on the rows beside it. And as you can see now, we got a new field in our data source where we have the protocol informations from our URL. So everything is working fine. And this is how you work with the left function. Let's go to the next use case where we want to extract the file extensions in our URL. So we want to get this part at the end from the URL. So as we are speaking about the right side, what we're gonna do now, we're gonna use the right function. So here we need to extract around 3 characters. Let's go and create the calculated field. So we're gonna go and create a new one. We're gonna call it URL file extension. So it starts with the keyword right, and then it needs as well 2 arguments. The string, our field gonna be the product image, and how many characters we want 3. So comma 3. So with that, you can see the calculated field is valid. Let's go and hit OK. And as usual, we have a new calculated field, a new dimension in our data source, just to deal with the file extensions. So let's check the values to see if everything is fine. And as you can see, we are getting all the file extensions from the URL. So as you can see, it's really simple. And we are with that generating new information additions, new fields that we could use in our analysis, and they are based on the original data that we get from the data sources. Alright, so now let's move to the next task where we want to get the URLs starting from the domain name without having the protocols. So we want to keep anything after the double slashes in the string. And this time we're going to use the Tableau function mid. Let's go and create a new calculated field. So we're going to call it product domain. And here we're going to start with a keyword mid. It takes 3 arguments. The first one, as usual, going to be the product image. And then when do we start cutting? So here we have to specify the number 1, 2, 3, 4, 5, 7, 8, 9. So we start cutting from 9. And the last one is optional. I'm just going to leave everything afterward. So we will not cut anything from the right side. So that's it. The calculation is valid. Let's hit OK. So as usual, we get a new dimension, new calculated field on our data pane to be used in the analysis. Let's go and grab it and put it in the rows to check the values. So as you can see, we start from the domain name and the protocol is cutted. The whole value gonna be the rest. And now next we have the following task for you. Alright, so the task says to extract the last 4 digits of the phone numbers from the customers and to go to the addresses and extract only the street name. So we're gonna remove the code and the word street. And now you can go and pause the video in order to complete the task, and once you are done you can resume it. Alright, I think it's really easy. So let's go to the small data source. We're gonna go to the customers and grab the phone to the view. Now we want to extract the last 4 characters. So we are speaking about the right side, right? We're gonna use the right function. Let's go and create a new calculated field. We're gonna call it phone code. And we're gonna use the right function to cut from the right, sorry. So the string value is phone, and we want to cut 4 digits. So we're gonna have the number of characters gonna be 4. So now the calculation is valid. Let's hit OK and take it to the results. And as you can see with that, it's really easy. We got the last 4 digits from the phone number. Alright, so now we're gonna go and solve the next task. We need only the street names from the address. So as you can see over here, we have the code and then the word street, and then we have the street name. We want only this piece of information. Since we want to start cutting over here, we're gonna use the mid function to define the starting point of the cut. So let's go and create a new calculated field. We're gonna call it address street. So we're going to use the function mid. The first value going to be the field address, and then the starting point going to be 9. The rest we're going to leave it as it is. So that's it. Let's hit apply and check the values. So drag and drop in the view. So as you can see with that, we have only the streets from the address. We cutted the first part. If you solve the task using like 8 instead of 9, that's because you forgot to count the white space. So if I just remove it and use 8, I might get exactly the same results, but we have white spaces, which is not really good. So the spaces counts. So it should be 9. So that's it. This is really simple. This is how you can extract informations in Tableau. Alright, so that's all about this use case, how to extract specific substring from the text using the 3 functions left, right, and mid. Next, we're gonna start talking about a bunch of functions on how to search for specific patterns in Tableau. Okay guys, so now we're gonna move to the next use case where we're gonna learn how to search for specific patterns in our text using calculated fields. And here we have 5 functions. We have start with, end with, contains, find, and find nth. And as usual, first we have to understand the concept behind them, then we're gonna go and practice in Tableau. So let's go. Alright everyone, so the search functions in Tableau are going to be split into 2 groups. The first one is going to return whether the substring exists or not in our text. And here we have 3 functions. We have the start with, end with, and contains. The output of those 3 functions is going to be always either a true or false. So we have a boolean. For example, we have the function contains, we have our string, and we are searching for dashes. So here the output is going to be either a true or false. In this example, it's going to be true since we have it here twice. And then we have a second group of functions where it can return the position of the string. Here we have 2 functions, find and find nth. The output gonna be the position number, so we're gonna get numbers out of those 2 functions. So for example, if we take the function find for the same string and we are searching for the dash, here we're gonna get the output of 6. So we are not getting true or false, we are getting the position of the substring. And here in this example can be the first one, it has the position number 6. So as you can see, both of them could be used to search for specific thing in our text, but they answer different questions. So the first group can answer the question whether the substring exists in my text, yes or no, true or false. But the second group can answer my question where I defined my substring. So here we're gonna get the position number of the search. So now let's go and focus on the first groups of functions. We're gonna focus on start with, end with, and contains. Okay, so now we're gonna start with the first one, start with. Let's say that we have the following text, monitor LG-4K. The syntax in Tableau gonna be very simple. So it starts with the keyword start with, and it accepts two arguments. The first one gonna be the string field. It is the text where we want to search inside it. The second one we're gonna have the substring. Here we're gonna specify what we are searching for. The output, as we learned, is going to be either true or false, so it is a boolean. So let's take an example. We have start with our text and we are searching for the word monitor. So let's see how this can work. It's really easy. So we start searching from the left and we move to the right. So the start position for the search is going to be the M character. So now Tableau gonna go and start matching the monitor here in our text starting from M. And as you can see here, the first part of our text is matching with the substring that we are searching for. So our text start with monitor, which is correct. So that's why Tableau gonna return it's true. Okay, so now let's take another one. Here we are asking, does our text start with the substring LG? Of course, if you are checking our word, if you start searching from the left to the right, our text does not start with LG, so Tableau will not find a match and it's gonna answer with a false. So that's it. It's simple, right? We are just asking a question. So we ask Tableau something and Tableau gonna answer with either yes or no. Okay, so now let's move to the next function. We have the ends with. It's exactly the opposite. All right, we're gonna work with the same example and the syntax in Tableau is very similar. So here it starts with the ends with. Here it accepts two arguments as well. The string field where we're gonna search inside it, and the substring here we're gonna specify what we are searching for. The output gonna be as well true and false. So let's start with the first example. We are asking here, does our text ends with 4K? So here Tableau gonna start searching from the right side, moving to the left. So now here, does our text ends with 4K? So yes, the last two characters is 4K, that's why Tableau gonna answer with yes. So that's it, the output, the result gonna be true. Let's ask another question. Does our text ends with LG? Well, if you check the text over here, it does not end with LG. LG is in the middle, so the last two characters is not LG. That's why Tableau gonna answer with false, so the answer is no. So as you can see, it's really easy. We are just asking questions and Tableau is answering with either yes or no. Let's move to the next one. We have the contains. Okay, so now we are working with the same example and the syntax is very similar to the other two. So here it starts with the contains and it accepts two things. The first one, we need to specify the text that we are searching inside it, and the next one we're gonna specify what we are searching for. The output gonna be as well a boolean, true or false, yes or no. Okay, so now let's ask Tableau the following question. Does our text contain the word monitor? So what Tableau gonna do is that it's gonna search everywhere. So it will not search at the start or at the end, it's gonna search everywhere. And if the word gonna be found anywhere inside our text, Tableau gonna answer with yes, with true. So does our text contain the word monitor? As you can see, it's true. So Tableau gonna return yes. And now let's ask another question. Does our text contains the word LG? Well, if you are searching over here, you can find it in the middle. So that's why Tableau gonna answer as well with true. So yes, our text contains the word LG. Okay, so let's move on and ask the following question. Does our text contain the substring 4G? So if you check the text over here, we have the 4, we have the G, but they are not together. That's why Tableau can answer no. We don't have the word 4G in our text. So now as you can see, the function contains does not have any restriction. It's gonna search everywhere. It's not like start with and end with. So the substring should not be at the start and at the end. If the substring exists anywhere, then yes, is true. If not, then is false. So that's it. This is about the three functions. Let's go now in Tableau and start practicing. Alright guys, so now you might ask me, what are the use cases for those three functions? Well, I use them in two scenarios. The first use case, when I'm exploring a new data. The second use case is when I'm offering new filters to the users. Okay, so now let's start with the first one, exploring the data. This is especially useful if you are new to a project or if you have a new data source. So the first step is usually to explore the data and learn the content of the data source. So if you are in this situation, you might have a lot of questions about the data. So you have those three functions, those three tools in order to explore the new data that you have. Okay, then let's go and explore the products inside our big data source. We have there a lot of products and I would like to understand the content of my data source. So let's take the product name to the rows, and as you can see, Tableau saying, okay, there is like a lot of members. I recommend to have only 1000, but I would like to see everything. So I'm gonna say add all members to the view. And now as you can see, we have a lot of products inside our data source, and I would like to understand the scope of my projects. So what are the content of those products? I would like to know whether we have Apple products inside our data source. So we're gonna go and create a new calculated field to answer that. So we're gonna say products starts with Apple. So that's it. We're gonna use the function starts with. So starts with, it need two arguments. The first one gonna be the text where we're gonna search inside it. It is our product name. So we are searching inside the product name. So now what we are searching for is the word Apple. So I'm gonna write it like this, and everything is fine. You can see the calculation is valid. Let's click OK. And as you can see on the left side, we have a dimension with the data type Boolean, because we have yes or no, true and false. So let's take it to the rows and check the results. You can see over here we have a lot of falses, and I'm gonna go and sort it in order to see the true. So we can see over here we have 4 products where the product name starts with Apple. The others does not start with Apple. So as you can see, now we have a little bit more insights about our data. Let's go and ask the follow-up question. Does the product name contains anywhere the word Apple? So not only at the start or at the end, anywhere. In order to ask the question, we're gonna go and create another calculated field. We're gonna call it products contains Apple, and we're gonna use the function contains. It needs 2 arguments. The string that we are searching inside it's gonna be our product name. So what we are searching for is Apple. So that's it, and the calculation is valid. Let's hit OK. Again, here we have a dimension called products with the data type true and false, so Boolean. Let's drag and drop it here, but first I'm gonna go and make it a little bit bigger to see the header of the field. So as you can see, the first one is contains, the second one is start with. So let's sort it by contains, and as you can see, we have around 7 products where the product name contains the word Apple. So now let's check the result. As you can see, the first one, we have it over here, the word Apple. The second one is over here, and the third as well over here, and the rest, those 4 products, they start all with the word Apple. So as you can see, with the contains functions, we're gonna get more results than the starts with. Alright, so as you can see, we are learning more about the products inside our data source. We have 7 products from the company Apple. Let's have the following question. Does the product's names ends with the word Apple? So in order to do that, we can create, and again, a new calculated field. Let's call it products ends with Apple. So we're going to use this time the function ends with, and again here we have the product name, and we are searching for the products. So does the product ends with the word Apple? The calculation is valid. Again, we have here a Boolean. Let's drag and drop it in the view to check the results. And now let's go and check the results. I'm just gonna make it a little bit wider to see. Okay, this is the ends with. Let's go and sort it. So as I'm sorting, we don't have any true. All the values are false, and that means we don't have any products where it ends with the word Apple. So with that, we understand that the word Apple exists only at the start of the product name or in the middle. So as you can see, those 3 functions are really great to understand our data. So now let's go and ask the follow-up question. Does the product name contains the word Samsung anywhere? So here we are searching for the product from the company Samsung. In order to do that, I think you already know it. We're going to go and create a new calculated field. We're going to call it products contains Samsung. We're going to use the function contains, and we're going to search inside the field name product name. This time we are searching for the word Samsung. So as you can see, the calculation is valid. Let's go and hit OK. So let's bring it to the view. So now I'm going to just make it a little bit bigger to see what we are talking about. So here it's about the Samsung. Let's go and sort the results. Wow, we can see that we have a lot of products from the company Samsung. So we have more products from Samsung than Apple in our data source. Let's check the result again. So here we have it over here, Samsung over here. Then we have a lot of products where it starts with the word Samsung, again here in the middle, but it never ends up with the Samsung words. Okay guys, so there is one more function that I usually use inside the calculations if I'm searching or exploring the data, and that is the case functions, the upper and the lower case that we learned before. And that is because Tableau is case sensitive in the search. So we have to pay attention how we are writing the search term. So in order to now overcome this problem, we're going to use the case functions. Let me show you an example. So now we're going to ask the question, does the product name contains anywhere the word black? Let's go and create a new calculated field as usual. We're going to call it products black, and this time we're going to use as well the contains, so the string, the product name, and we are searching for the word black. So that's it. Let's hit OK, and we have it as a new dimension. Let's check the result as usual. I'm just going to make it a little bit wider to see the results. So now we have a lot of falses, and we have as well a lot of true. So there is like a lot of products that has the word black. So as you can see over here, we have here black. We have over here as well the word black at the end, and so on. So there's like a lot of products with the word black. So the case here is the capitalized of only the character B. Let's go and change the case in the search term. So we're going to go and edit the calculations. So now instead of the first character capitalized, you're going to have it as small. So everything in the lowercase. Let's go and hit apply. So now as you can see in the results, we have only one product with the word black as lowercase. So Tableau is very sensitive with the cases inside the search term. And if we switch everything, for example, to uppercase, black, let's search. So as you can see, all the products that we have is now false. We don't have any products that contains the word black in uppercase. So Tableau is very sensitive about the cases inside your search term. So now to fix this, instead of going and changing each time the case of the search term, so lowercase, uppercase, capitalized, and so on, we go to the product name and we force it to be uppercase or lowercase using the lower or upper. So we're going to go over here and add, for example, the lower. You can use upper if you want. We're going to have the same results. So with that, we are first forcing the product name to be lower, and then we're going to search for the word black. So with that, I'm covering all the scenarios inside my data source. So let's go and hit OK. So with this, I will get all the products that contains the word black. Doesn't care whether it is lowercase or uppercase, we're gonna get everything. So with that, I'm sure that the string is containing the word black and we are not missing anything. So that's why I include the upper and lowercase inside the calculations before I start searching. So that's it for the first use case. This is how I usually use those three functions in order to explore and learn the content of my new data source. Let's go now to the second use case where we're gonna use those three functions in order to offer new filters to the users. So for example, let's create a filter for the companies inside the product's name. So let's go and create a new calculated field. We're gonna call it companies. And this time gonna be a little bit more complicated than before, but we're gonna do it step by step. So we are searching first for the company Apple. So we're gonna have contains product name, and the search term gonna be Apple lowercase, but we have as well to lowercase the product name, right? So lower, and we're gonna have it like this. So this is the first one. I'm just gonna copy it and paste. For the next company, we're gonna have Samsung, and then we're gonna have Microsoft. So we are searching for those three companies, and that's it. So now we're gonna have those three companies. But as you know, the output of the contains is always like true and false. But I would like to have a value in my filter called Samsung, Apple, and Microsoft. In order to do that, we're gonna use the logical operations if-else statements. Don't worry about it, we're gonna have a dedicated tutorial for that later, but we have to use it now. So now just follow me, we're gonna use it to evaluate those conditions. So it starts with if for the first one. So if contains the product name Apple, what can happen? So then I would like to see the value Apple. And then if it's not true, then go to the next one, else if. Then we're gonna evaluate this condition. If it's true, then it's gonna be Samsung. Then if it's false, of course, we're gonna use another else if. We're gonna evaluate this one, and then the output, if it's true, gonna be Microsoft. So that's it. If doesn't fulfill any of those conditions, we're gonna have the else, let's say unknown. So that's it, we're gonna end it. Don't worry again about those logics, we're gonna talk about it later. So with that, I'm gonna get values. I'm gonna get those three values instead of true and false, and we are evaluating those conditions. Let's go and hit OK. So as you can see now, we have new dimensions. The data type is not Boolean, not true and false, and that's because the output of the calculation now gonna be string values. Let's go and show it as a filter. And now we can have those values, as you can see, Apple, Microsoft, Samsung, and unknown. I'm going to add it as well to the view to see the results. So let's go and grab it over here. So now the users can go and start filtering the data based on the companies. So let's remove everything and start with Apple. So with that, we're going to get all the products with the word Apple inside it. Or we have Microsoft, so now we can see those products are from Microsoft. The same goes for Samsung. So with that, we are filtering based on the companies, and we use the product name as basics for that. And the unknown, I think, gonna be a lot of values unknown. You can go like step by step, adding more companies to our filters, but now I just show you an example for that. So this is exactly the power of the calculated fields in Tableau. We introduced new informations based on the functions. So this is all for this use case, how to create filters based on those three functions. Alright, so now we're going to focus on the second group of search functions in Tableau. We have the two functions, find and find_nth. Here we are answering the question, where do I find my search term? So we are searching for the position number of a search term. So this time we are not getting true and false, we are getting the position number. So let's understand why do we need this. Alright, so now let's quickly understand the differences between find and find_nth. Well, in find we are returning the position number of the first occurrence. In the find_nth we are returning the position number of specific occurrence. So for example, let's say that we want to search for the position number of the dash inside this string. So here the result is going to be 6 because the first occurrence is going to be at this position. But in the other hand, we can use the function find_nth for the same text and for the same search. So we are searching for the dash, but we are asking now the position of the second occurrence. So the first occurrence is going to be ignored. We're going to get the position of the second occurrence, and that's going to be 10. So this is the main differences between those two functions. In find, we are searching for the first occurrence always, but in find_nth, we can specify which occurrence we are searching for. So let's go more in details about the function find. Alright, so now we're going to have this example, and as you know that each character in the string has a position. So C has the position number 1, and the character 5 has the position number 14. The syntax for find in Tableau is as well very simple. So it starts with the keyword find, and here we have 3 arguments. The last one is optional. So string is the text where we're going to search inside it. The substring is what we are searching for, and here the start position of the search. So as I said, it is optional. The output going to be a number. So for example, let's say that we want to know the position of the dash inside this text. So how this works, it's really easy. It starts from the left side always, and since we didn't specify anything for the starting position, it's going to start from the first character. So Tableau going to start searching. Okay, in the first character we don't find it, so the dash we can find it at the position number 6. So the output going to be at the position number 6. Alright, so now let's take another example where we can specify the start position for the search for Tableau. So we're gonna have the same thing again, but we're gonna say this time start from the position number 7. Okay, so what's gonna happen? We're gonna start searching from here, and Tableau gonna start from left to right. So we're gonna find it over here at the position number 10. So the result gonna be at the output 10 instead of 6 because we start searching from this position. Alright, so that's all for the function find. Let's move to the next one. We have the find_nth. We're gonna work with the same example. The syntax gonna be a little bit different. So it starts with the keyword find_nth, the string value where we're gonna search inside it. We're gonna specify what we are searching for, but this time we're gonna specify the occurrence. So here we have to tell Tableau which occurrence we are interested in. Let's take an example. We have the following question: find the position number of the dash inside this string, but we are interested in the second occurrence. So how this is gonna work? We're gonna start searching from left to right as usual. Here we cannot specify the start position of the search, so we don't have this option over here. It's gonna always start from the first one. So as we are searching from the left to the right, we have the first occurrence of this character. So we have it at the position number 6. So here the output will not be the position number 6 because we told Tableau we are interested in the second occurrence, not the first one. So Tableau gonna go and keep searching for the dash in the string. So we're gonna find it at the position number 10. So here is the second occurrence of the dash inside our text. So this is exactly what you are looking for. The output gonna be the position number 10. So that's it. This is how this function works. We're gonna search for specific occurrence. In the function find, we're gonna get always the first occurrence, but there we can specify where to start search. So now let's go in Tableau and start practicing. Alright, so now we're gonna have the following example. We're gonna start with a small data source. Let's go to the customers and I would like to get their first name and as well the phones. So now the task is to extract the country code from the phone and to put it in extra field. So we are interested in those informations, the plus 33, plus 1, plus 49, and so on. So as we learned before, we can use the function left in order to extract the informations from the left side in the text. So let's go and create that. So we're gonna go and create a new calculated field. Let's call it phone country codes. And we're gonna use the function left. We have to specify the string, so it's going to be the phone. And now the next one, we have to specify the number of characters that we want to extract. And here exactly where the problem comes. So sometimes it's going to be like 3 characters and sometimes it's going to be 2 characters. So let's go, for example, with the 3 and let's hit OK. We have it over here, new dimension. Let's just bring it to the view. And here we can find exactly the issue, right? So the first one is fine. The third one as well fine. But for those countries, it's not working. We have the dash inside it, which is not really correct. And now in order to fix this, we're going to use the magic of the function find. So if you check over here, we want always the numbers before the dashes, right? So we can search for the position number of the dash, and then we can include it in the left function. So let me show you what I mean. We're going to go and create a new calculated field. We're going to call it phone find dash. So now we're going to go and find the position number of the dash. So as we learned, it starts with find. We have to specify where we're going to search. So we are searching in phones, what we are searching for, right? We're going to have the dash here and that's it. We are not interested in the start position. So we're going to start from the first character. So that's it. As you can see, the calculation is valid. Let's hit OK. And since the output is going to be a number, we're going to get it as the continuous measure. So let's drag and drop it over here and see the results. So the position number of dash inside the first phone is 4, the second one 3, then 4, 4, 3, everything is fine. So now the next step, what we're gonna do, we're gonna bring those 2 calculations, the left and find, in one calculation. So I'm gonna go and copy the syntax from the phones find dash. Let's just copy it from here and go back to the first calculation about the country code. So let's go over here, edit it, and now instead of having this 3 as a static, we're gonna have it as a variable using the find function. So let's just add it over here. So now how Tableau gonna execute this calculation? It's gonna start with the first function find. So it's gonna first find the position number of the dash inside the phones, and then afterwards we're gonna go to the function left outside. We're gonna now cut everything after this position number. Alright, so now let's go and check the results at the string. As you can see, we are almost there. So we have the plus 49 dash, plus 1 dash, plus 33 dash. So the dashes are everywhere, and that's because we are cutting everything after the dash position. So that means we are always one step more than needed. So in order to fix it, it's really easy. We're going to go back to our calculation. Yeah, we are getting here the position number, which is correct, but we want to get one step back. So in order to do it, we're going to do -1 to go one step back. Let's hit OK. Alright, so with this, we get exactly what we want, right? So plus 33, plus 1, plus 49. And with this, we're going to get more dynamic in the function left if we are using the find function. So with that, we can see how we can bring those functions together in one calculations in order to achieve such great goals. Alright, so now let's try out the second function that we have, the find nth. So now let's say that we want to get the position number of the dash, but in the second occurrence. So let's go and create a new calculated field. We're going to start with the keyword find nth. It needs 3 arguments. The first one going to be the text where we're going to search inside. It's going to be the phone. And then we are searching for the dash. And then the third one, we're going to specify which occurrence we are interested in. So we are interested in the second one. So that's it. The calculation is valid. Let's click OK. So since the output is number, we're going to get a new continuous measure. Let's bring it to the view over here. So now let's check the results. For the first phone, the second occurrence of the dash going to be at the position number 8, which is correct. And as you can see, the find is number 4 because the first occurrence at the position number 4. For the second one, it's going to be the number 7, which is as well correct. So now let's go and start changing those occurrences. Let's go and edit it again. I would like to get now the third occurrence. So as you can see, we have a third dash over here. So let's change it to 3 and just apply. You can see now we are getting the position number 12 for the last dash in the phone number. So with that, we are getting the third occurrence of the dash inside our text. But now if we go and switch it to 1, what can happen? We're gonna get exactly the same result as find, because find gonna always bring the first occurrence. So here we are saying I'm interested in the first occurrence. Alright guys, so that's it for those two functions, find and findNth. They are really useful to get the position number of specific substring, and I usually use them in another calculation, so they are like supporting another function. Alright, so with that we have learned how to search for specific patterns in our text in Tableau using Tableau calculations. Next we're going to start talking about another group on how to combine and split the data in Tableau. Okay, so now we're going to learn how to combine and split the text in Tableau using the concatenation operator, the plus, and the split function. But as usual, let's understand the concept behind them, then we're going to practice in Tableau. Let's go. Alright, so now we're going to talk about the concatenations in Tableau. It's very simple. We use for that the plus operator in order to combine multiple text into one text. For example, in our database, we could have the following scenario where we have the first name and the last name separated from each other's using different fields. So we would like to have only one field called the full name. So for example, in order to do that, we can use the plus operator in order to combine the first name Michael with the last name Scott, and at the end result, you're going to get the full name Michael Scott. But now if you check the full name, we would like to have always a separation between the first name and the last name in the output inside the full name. So we usually use a space between them. So we're going to do the same. We're just going to add one plus operator. So we have Michael space Scott. So between Michael and space, we're going to have the plus operator, and between space and last name, we're going to have as well another plus operator. So the output going to be Michael space Scott. So as you can see with the plus operator, we can structure anything we want by combining multiple string values together using the plus. So that's it. This is really easy. Let's go back to Tableau and start practicing. Alright, so now we're going to go to the small data source over here, and we go to our customers. We would like to have the first name and the last name in the view, and as you can see, those informations are separated in two different fields. So the task says now to create only one field for the customer name, the full name, instead of having two. In order to do that, as usual, we're going to go and create a new calculated field. We're going to call it full name. Now we need the first part, the first name, and then after that, we're going to have the plus operator. Then we want to have a separator between them as an empty space. So we're gonna have it like this, and then plus operator. The last part gonna be the last name. So let's take the last name and put it over here. So that's it. It's important that the calculation is valid, so everything is fine. Let's hit OK. So now as you can see in the data bin, we have a new calculated field, a new dimension called full name. Let's check the values. We're going to drag it over here on the rows. And as you can see now, we have a very nice full name, George Pips, John Steele, and so on. It's really simple, right? So now if you change your mind, you would like to have like a dash between those names. What we're going to do, we're going to go and edit it. Then instead of having the white space over here in the middle, we're going to have the dash. So that's it. Let's hit apply. And now we can see in the full name that the first name and the last name are separated with a dash. So it's really simple. Let's take now a quick task. The task says to combine the category and the product using the following rule. As usual, you can pause the video in order to complete the tasks. And once you are done, you can resume it. Alright, so now let's check the solution. It's very simple. We're going to go to the products. Let's first see the raw data. So we have the category and the product name. And now we're going to go and create new calculated field. So we're going to call it full product name. So the rule starts with the category, then we have our plus operator. After that, the separator gonna be the double point, but after the double point we have a white space. So I'm just gonna add it over here. Then we have a plus, and we're gonna have the product name. Let's check the results. The calculation is valid. Let's click OK. And here we have our new dimension. Let's just drag and drop it over here and check the results. Just gonna make it a little bit bigger so we can see the results from here and here as well. So as you can see, our product name now starts with the category, double point, then the product name. And that's it. This is how you can work with the concatenations in Tableau. It's very simple, right? So now we're gonna learn the exact opposite. So we're gonna learn now how to split one field to multiple fields using split. Alright, Alright, so now we're going to talk about the split function in Tableau. It's a very important function and a lot of people get confused about it, but I think it's simple. So let's check this example. We have here one field with a lot of informations. So we have here the product name, the product ID, and the product code all in one field. And in many situations, in the analysis and the visualizations, I would like to split those informations into 3 fields. So instead of having one field, I would like to have it in 3 fields. So in order to do that, we can use the split function. And before we learn that, we can do that with the left, right, and mid, but the split function is easier in such a situation. So we want to split this field into the product name, the product ID, and the product code. And in Tableau, we have the following syntax in order to do it. So we have split, and it needs 3 arguments. The first one is the string, the text that we want to split it. So now let's go and check the syntax in Tableau. It starts with the keyword split, and it needs 3 arguments. The first one going to be the string or the field that we want to split. The second one going to be the delimiter, and then the last one, the token number. The output going to be a string value. So now let's take an example. I would like to split this text, and the delimiter going to be the dash, and I would like to have the token number 1. So here Tableau needs from you 2 informations, the delimiter and the token number. So the delimiter is the separator between words. So for example, we have a separator between canon and the ID using the dash, and we have another separator between the ID and the code. So those dashes are the delimiter that splits my text. So Tableau here wants to understand from you how the words are separated inside the text. Now let's move to the next information that is needed, the token number. Here as well, Tableau wants to understand which part of informations you are interested in. Is it the first part, the second part, or the last part? So here we have like an ID or token for each piece of information. So the first one gonna has the token number 1, the second one we have token number 2, and the last one is the token number 3. In this example, we said I'm interested in the token number 1. That means I'm interested in the product name. So the output gonna be canon. And of course, if you are interested in the product ID in the middle, we could say, okay, I'm interested in the token number 2. So if you specify it like this, you will get the product ID. And if you are interested, of course, in the last one in the product code, you can specify the token number 3 in order to get the product code. So as you can see, once you understand it, it's really easy. We just need to informations, what is the separator between words, and which token number you are interested in. So now let's go back to Tableau and start practicing. Alright everyone, so there are 3 ways on how to split your data inside Tableau. The first one is by creating new calculated field. The second one is automatic split. The third is customized split. So we're going to start with the first one on how to split your data using new calculated field. We're going to take the following example. We're going to stay with the small data source. Let's go to the customers and grab the phones over here. And the phone numbers has a structure. So we have a country code, area code, and the phone number itself. So now we would like to split those 3 informations into 3 new fields. Okay, so let's see how we can do that. So we're gonna go as usual and create a new calculated field for the first part, for phone country code. So we're gonna start with the split keyword, and it need 3 arguments. The first one gonna be the string that we want to manipulate. So it's gonna be the phone number. I'm gonna add it like this. Then the delimiter. The delimiter here is the dash. So as you can see, those stuff are splitted with the dash. So let's just add it over here. Then Tableau needs from me a token number. So the first one gonna be the token number 1, then 2, 3, 4. So we have 4 sections, and we are interested in the first token number. So the first one. So let's add 1. And that's it. As you can see, the calculation is valid. Let's go and hit OK. So now we can see that on our data pane in the data source, we have our new field, the country code. Let's go and grab it to the view and check the result. And with that, we are extracting the first token, the first part of the phone. And with that, we have our country code. Everything is perfect. So now the next step, we would like to go and extract the area code. So the token number 2. So now we're going to go and create a new calculated field. But first, I would like to take the old code because we want only to adjust the token number, because everything else can stay the same. So let's go and create a new one. We're gonna call it phone area code, and then we're gonna put our code over here. The same stuff gonna stay, the phone and as well the dash as separator. Then we want to change only the token number 2. So we are speaking about the second part. So let's go and hit OK and check the results. We have here again our new field. So drag and drop it on the view, and as you can see now we are splitting, yeah, the second part. So we have here 555 and as well over here. So with that we got the third part from our phone. We have now the country code and as well the area code. And now next we have the following task for you. Create a new field in the data source to extract the phone number part without the country and the area codes. Now you can pause the video in order to complete the task, and once you are done, resume it. Alright, so now we're gonna go and create a new calculated field. We're gonna call it phone number, and we're gonna have the same script. So we have split phone dash, but this time we are interested in both token 3 and token 4. So how we can do that in Tableau? We can add only one token at a time. So in order to do that, we're going to go and change this to 3. And since we need both of the informations in one field, we're going to use the plus operator. So what we're going to do, we're going to go over here, plus, and then we're going to add the same code over here, but this time for the token number 4. So with that, we are getting both of the tokens in one field. So the calculation is valid. Let's hit OK. And as usual, we got a new field in our data source. So let's check the result over here. We can see that now we have the phone numbers in this field. So now as you can see, the first one is 1, 2, 3, 4, 5, 6, 7, and we have it as well over here. So we have as well the same phone number. But you might say, you know what, we are missing the dashes, right? So we can go and add them in our calculated field. So let's go and edit it, and we just can add new plus operator, and between them we're gonna have the dash, right? So as you can see, the calculation is valid. Let's go and hit OK. And with that, we got exactly the same structure from the phone. So that's it for the first methods on how to split your data using new calculated field. You can see from one field, we have extracted 3 new fields. So now let's go to the second method where we can split the data using automatic split. Alright, so now let's see how we can do that. So we're going to stay with the small data source. This time we need the URL. So let's take the product image from here, drag and drop it in the view. And we know that in the URL, there is a lot of informations, and as well, we can use the splitter to split the data. So now instead of creating manually those calculated fields, there is a really nice feature in Tableau where we can split the data automatically. So in order to do that, we're going to go to our field, the product name, right click on it, and here we have the option of transform. So we are manipulating the data, and here we have 2 options, the split and the custom split. So the split is the automatic way. Wow, we got now a lot of new fields in our data source, and that's because Tableau automatically split the data and as well understood the content of the data. So you can see here we have the product image, domain, then fragment, path, query, schema. All those informations are part of the structure of an URL. So now let's go and check those informations. We're going to take, for example, the domain, drag and drop it on the view, and as you can see, Tableau got it correctly, right? We got now only the domain information from the whole URL, which is really nice. We can take as well the scheme over here, and we have the protocols from the start. So as you can see, Tableau got it really correctly. Some of those fields gonna be empty, I think, because we don't have it as a part in our URL. So with that, Tableau did the automatic split, and if you would like to learn how Tableau did split it, you can find it as well inside this field because it is calculated field. So let's see how Tableau did split the domain. Right click on it and go to edit. So as we can see here, Tableau is using 2 splits in order to get the domain informations. The first split is this one. So Tableau is splitting the protocol from the whole URL. So the separator gonna be the double point and the 2 forward slashes, and we are taking the token 2. So we are getting the second part. So once we get the second part, it's gonna be really easy. The separator, as you can see, is the forward slash. So we want to split now with the forward slash, and we would like to get only the first part. It's really easy. You can go and try it yourself. So that's it. Let's click OK. So with that, Tableau is, in some cases, not in all cases, is smart enough to split your data into new fields automatically. So that's it for this method, the automatic split. Next, we're gonna see the customized split. Okay, so we're gonna stay with the small data source, and we're gonna go to the customers. Again, here we want to split the phones using the custom split. So let's bring it to the view, and then in order to customize the split, we're gonna go to the data pane on the field that you want to manipulate, right click on it, and then here we have transform. Before we have the automatic split, this time we are interested in the custom split. So let's go inside, and here we're gonna get a new window in order to customize the split, and it's like the calculations, the syntax. Tableau needs from us 2 informations. First, the separator. Second, what do you want exactly to get? So the token numbers. The first one, the separator or the delimiter, in this example gonna be the dash. All those informations are splitted with the dashes. So let's go and enter a dash. The second information, we have the following options. So split off, and here we have 3 options. Do you want the first part, the last part, or everything? And here it depends on what do you want. If you want to split everything you want for each piece of information in new fields, you're gonna go with the option all. So now let's say that you are interested only in two informations, the country code and the area code. The rest you are not interested to have it in the data source. So in order to get the first two parts, we're gonna go over here and select first, and here you can specify two. So we are interested in the first two columns and the first two informations from the left side. But now let's say that you are interested in the last two parts. So you would like to get two fields for the last two informations. So what you're gonna do, you're gonna go over here and select last, and as well select two. So with that, you are specifying for Tableau what do you want exactly to get as a result, how many fields from the start, from the end, or everything. So in this example, I'm interested to get everything, so we're gonna go with the option all, and that's it. Let's go and hit OK. So once we do that, Tableau gonna go and create a lot of new fields. So Tableau did manage to split the phone number into 4 parts. So let's go and check those informations, drag and drop it over here on the rows. And as you can see, the first part gonna be the country code, the second one gonna be the area code, and then Tableau split those two informations into 2 fields. So here it's not like the second method where we are blindly automatically splitting everything. Here we are specifying for Tableau few rules, and then Tableau gonna go and as well automatically split the data to get better quality in the fields. And of course, if you are interested on how Tableau did the split, we can always go to the data pane. All those informations are calculated fields, and we can go inside them and check the code. So we can go over here and do edit, and as you can see, the delimiter is the dash, and Tableau get it as a first token in order to get the country code. Alright guys, so that's it. Those are the 3 methods on how to split the data inside your data source. They are really useful in order to generate new informations and split those complex structures inside the original data source into new structure for the analysis in the visualizations. Alright everyone, so that's it. This is how you combine and split the text in Tableau. Next, we're going to start talking about the last string function in Tableau, the replace. Okay, so now we're going to learn about the last use case for the string function, how to replace specific substring with another substring using the replace function. As usual, let's understand the concept behind it, then we're going to practice in Tableau. Let's go. Okay, the replace function in Tableau, it's very simple. It's gonna replace one substring with another one. So for example, we're gonna have the following address, and as you can see in the middle, we have the abbreviation of the street, so st dot. So I would like to have a normal wording of this. So instead of having the abbreviations, I would like to have the complete word street. And we can do that using the replace function in Tableau. Let's check now the syntax in Tableau. So it starts with the replace keyword, and it needs 3 arguments. The first one is gonna be the string, the original text that you want to manipulate. The second one is the substring, the one that you want to replace. The third one is the replacement. So it's really clear. This is going to be the new substring, the new word. So here the output going to be as well a string value. So in order to solve this task in this example, what we're going to do, we're going to use replace, then our text, then the old one going to be the st dot, the abbreviation. This is the old substring, and the new one going to be the street, the complete word. So how this going to work? Tableau has first to search for the substring that we want to replace. So it's going to search the whole text in order to find the substring. And in this example, of course, we're going to find it over here in the middle. And the next step is that Tableau gonna go and start replacing this word with the replacement. So Tableau gonna take the st dot and gonna replace it with the complete word of street. So at the end, we're gonna get Louis Street, Paris. So as you can see, it's really simple. We are replacing the old value with a new value. So at the end, the string gonna look like this. So we're gonna have street complete instead of st dot. So now, of course, the question is, what can happen in the output and the results if we don't find anything? So for example, we have this address and Paris. We are searching for the st dot, but we don't have it inside the text. So here Tableau gonna return the original text without changing anything, so nothing gonna happen. So that's it. It's really simple, right? We're gonna go back now to Tableau in order to practice the replace function. Okay, so now we're gonna go and practice with the small data source. Let's go to the customers, and we're gonna manipulate the phone number again for the customers. Now, as you can see, the structure in the phone number starts always with the plus for the prefix for the international call. So now we have the requirement to replace the plus with 00 as a prefix. And now in order to do that, we're gonna use the replace function in Tableau in order to do the switch, the replacement. So let's go and create a new calculated field. We're gonna call it phone replace. So it starts with the keyword replace. We need now the field that we want to manipulate. It's going to be the phone number. So we have it over here. And now we need to specify for Tableau the substring, the old value. So the old value is the plus sign. And now we have to specify for Tableau the replacement, the new value. The new value gonna be 0, 0. So that's it. Tableau has the calculation as a valid. So let's go and hit OK. And with that, as usual, we created a new calculated field in our data pane. Let's go and check the results. So drag and drop on the rows. And now we can see in the result, instead of having the plus sign, we have everywhere 0, 0. And with that, we have fulfilled the requirement. And now we might get another requirement where they say, you know what? I don't want those minuses inside the phone number. So it would be nice to remove them. And now in order to do that, we're gonna do the same thing. We're gonna use the replace function. The old value gonna be the dash and the new value gonna be nothing. Let's see how we can do that. So now let's go and edit our calculated fields. We just want to add new replace function. So let's go edit over here. And here it doesn't matter whether we want to replace first the plus or the dash. So now in order to do that, I usually do it like this. If I'm doing nested, so replace. So what we are replacing? The phone number. So instead of having the dash, we're gonna have nothing. So we are replacing the old value, the dash, with nothing. So now in order to have it nested, I would like to take this part, the first one, and put it instead of the phone. And with that, we are having nested calculations. First, we're going to replace the plus sign. Second, we're going to replace the dash sign. So let's take it to the first row. And with that, Tableau is saying the calculation is valid. Let's go and hit OK. And as you can see now in the results, we don't have any dashes or a plus sign. So we have a whole number without any special characters. So with that, we solved the second requirement. So it's easy, right? It's not that hard. And we can do a lot of things with the replace function. It's a great function to manipulate the string values in Tableau. So now for you, we have the following task. In the big data source, in the product name, we would like to replace the hash symbol with a number as abbreviation. And now you can pause the video in order to complete the task. And once you are done, you can resume it. All right, so we're going to go to the big data source this time, and we're going to go to the products, and we need the product name. Let's drag and drop it on the view and check all values. So now we're going to make it a little bit bigger in order to see more values. So inside the data, we have some hashes, like here, for example, at the start, and we want to replace it with in our point. So in order to do that, we're going to go and create a new calculated field. So let's go on the arrow over here, create a new calculated field. We can call it product replace. So we're going to start with the replace keywords, and then we need the string that we want to manipulate. It's going to be the product name. The next, we want the old value. So it is the hash, and then the replacement gonna be the number as abbreviation, so in our point. So that's it. As you can see, the calculation is valid. Let's go and hit OK. So with that, we have a new dimension, new calculated field in our data pane. Let's drag and drop it in the view and check the values, and we see over here, instead of the hash, we have the abbreviation of the number. So with that, we have learned that the replace function is very simple and as well very important in many use cases. I use it a lot once I want to clean up the data. So sometimes we get bad quality from the sources and there will be a lot of like special characters. I can use always replace to clean up the data and to remove those special characters with something more meaningful in the visualization. Like we did in this example, we replaced those special characters with something more meaningful. Or I use it a lot as well to change the format of something. So for example, we here have the phone numbers and we change the format from having the dashes to something else like without dashes, and as well instead of the plus we have the 00. So with that, we are not cleaning up here the phone, we are changing the format and how we are presenting the phones in the visualizations. So on the left side we have the plus and dash, on the right side we don't have them. So we usually use the replace function in order to change the structure, the format of one field. It is just amazing and very important tool in Tableau. Alright everyone, so that's all for the replace function, and with that we have covered all the use cases in the string functions. We have learned around 16 string functions to manipulate, transform, and clean up the text values in Tableau. Next, we're gonna jump to another group of functions in Tableau, the date functions. Alright, so now we're gonna talk about the third group of functions under the category row level calculations, the date functions. And there are three use cases for the date functions in Tableau. The first one is to extract specific date part from our date, like a day, year, and month. And for that, we have 6 different functions in Tableau: the date part, date name, date trunc, day, month, year. The second use case is to add and subtract date values in our data source. So here we have two functions, date add and date diff. The last use case is to find and fetch the current date and time. And here we have two functions, today and now. So those date functions gonna give us a tool to manipulate and transform the date values in Tableau. We're gonna start now with the first use case, how to extract specific parts from the dates using those functions. And as usual, it's really important to understand the concept behind them, then we're gonna practice in Tableau. So let's go. Alright everyone, so in Tableau there are two ways on how to manipulate, transform the fields with the data type date. The first one is to do it globally in the data source for all worksheets, all workbooks. The other way is to do it locally, only in one worksheet, only in one view. So for the first one, if you are manipulating the date and you want to reuse it in different worksheets, so in order to do that, we can go and create new calculated fields using the date functions. But now on the other hand, if the transformation is not that important, you don't want to reuse it, you don't want to use it in any other worksheets, you need it only once in one view, then instead of creating new calculated field in the data source and using the date functions, we could just simply go and change the date format directly in the view, which is way easier and quicker than creating new calculated fields. So as you can see, there is like two methods on how to manipulate and transform the dates in Tableau, either using the date functions or changing the date format. And now if you ask me which method should I use, you have always to ask the following question. Is the transformation going to be needed in different worksheets? Then yes, go and create a new calculated field using the date function. But if the transformation is only needed for one view, then you have to change the date format directly in the visualization. So now we're going to go and focus on the date functions since we are talking about the calculations, and at the ends we're going to talk about the date formats. Alright everyone, so in Tableau we got a bunch of date functions that all has the same goal, to extract date parts from specific field, and we can use them to generate such a view. So as we can see over here, we have the years, we have the months, the quarters, all those informations comes only from one field, the order date, and we can build from all those new information that we extracted a lot of analysis and insights about our data, like the one that we are seeing here, the heat map. So now let's go first understand those functions and then we come back to Tableau. Alright guys, so now we're going to talk about the first date function in Tableau, the date part. We can use it in order to extract a piece of information from our date fields. So for example, we have the following date. It is structured from year, month and a day. We can use date part to extract one piece of information, like for example the year. So if we are extracting the year, the output gonna be 2025. But if we are extracting the months, we're gonna get the August 8. And if we are extracting the day, we're gonna get 20. And here it's very important to understand that if you are using the date part, the output gonna be in number. So the year gonna be in number, the months will not be August, it's gonna be in number, so it's gonna be 8. Same thing for the day, so you will get 20 as a number. So let's see the syntax in Tableau. It's very simple. So it starts with the date part, then Tableau needs from you two informations. The date part, here Tableau can ask you which piece of information you are interested in. Do you would like to have the year, a month, a day and so on, and the second part, the second argument is going to be the date field that we want to manipulate, and the output, the result of this function, going to be a number. So now let's take an example. We're going to take date part. Now we are interested in the information of day, so we would like to extract the day information. Then our date going to be looks like this, the output going to be 20. If we want the month, then we have to specify a month at the date part, and if we do it on this date, we will get the month 8. The same thing if you want to get the year. So here we specify the year at the start, then our date, the output can be 2025. So that's it for the date part. This is one method on how to extract a date part from a specific date. Let's move to the next one. We have the date name. Let's see the syntax in Tableau. It's exactly the same. So it starts with the date name as a keyword, then Tableau needs from you two informations, which part of the date you are interested in, and give me the field that you want to manipulate. But this time the output can be a string value. So let's take an example. Let's say that we are interested in the year part from our date. So the output can be again 2025, but the value gonna be in the data type string. But this time, if you say, you know what, I'm interested in the month, so you specify a month as a date part, this time Tableau gonna answer with August instead of 8, because the output here is string. So you will get the name of the month as an output. And now the next one, if you say, I'm interested in the day, so if you specify in the date part a day instead of month, you will get as well a 20, but as a string value. So that's it for the date name. It's very similar to the date part, right? But the only difference is that there you are getting a number, but with the date name you are getting a string value. So this is another method on how to extract the date parts from a date. Let's move now to another set of functions that could be used as well to achieve the same goal in order to extract dates parts from a date. So this time we have 3 quick functions in order to extract quickly the date part from a date. They are my favorite. I tend always to use them in compared to the other 2 because they are really easy to write. So the syntax in Tableau gonna look like this. The first function, it accepts only one argument, a date. Same thing for the month and for the year. The output gonna be a number, so it's like the date part function. So for example, if I'm interested in the day, I can do it like this. I use the function day, then the date that we want to manipulate, then the output gonna be 20. As you can see, compared to the others, it's really quickly to create, right? So here we don't have to specify for Tableau in the syntax the date part because the function name called day. The same thing for the month. If I'm interested only in the month, I can just use the function month in order to extract the August or 8. And for the last one, if I'm interested in the year, I can use the function year. So as you can see, they are really easy and quick to create if you compare it to the other 2. So as you can see, they are really easy. Let's move on to the next one. This is gonna be slightly different than all others. We have the date trunk. Okay, so some facts about this function. It is a little bit complicated. A lot of people don't know about it, but I tend to use it a lot. It's a very useful function, but it is not that famous. Think about the date trunk like a rounding function in numbers. So if you have a lot of details in one date, you can round the date to specific level. So what this means, if we have the following date time, so we have here like hierarchy, right? We have a year, month, day, hour, minute, and seconds. So we are seeing in this data a lot of informations, and sometimes you are not interested in a lot of details like seeing the seconds, minutes, and hours. You would like to see only at the month level. So what we can do, we can use the date trunk in order to round those numbers. Let's check first the syntax in Tableau. It's very similar to the others. It looks like this: date trunk, then you specify the date part, and then the date that you want to manipulate. The output this time, it will not be a number or a string, it's gonna be date and time. Okay, the best way to understand this function is to have some examples. So let's say that we specified at the date part a day, and then we have our time and day over here. Then what gonna happen, what you are telling Tableau, that the time informations are really detailed for me, and I'm interested only to see this piece of information at the day level. So I'm interested only at the day informations. I'm not interested in the time. So what can happen in the output is that Tableau gonna return the same informations, but this time it's gonna reset everything at the time. So you can see we are maintaining all the informations about the year, month, and day, but anything below the day is gonna be resetted to zeros. So as I said, it's like rounding numbers, right? You are rounding the information to a specific level. So now let's move to the next level where you say, you know what, I'm interested at the month level. So you specify at the date part a month, then we're gonna have the same information over here. So what you are saying to Tableau is that I'm not interested in the details in the day. I would like to see my information at the month level. So with that, we're gonna get the 1st of August in 2025. Now we're gonna go one more step where we're gonna say we are interested only at the year level. So if you go and specify at the date part, the year, what's gonna happen? You tell Tableau, I'm not interested in anything else. I'm just interested in the year. So I think you already got it. What's gonna happen? Everything gonna be resetted. So anything below the year, so the month, the day, the time, gonna be resetted to 1 over here, then zeros at the times, and we're gonna have only the value 2025. So that's it for this function. It is very useful in many calculations to use the date trunk. So now let's go and compare all those functions side by side. We have here as a rows the date parts, so we have year, quarter, month, day, and so on. And then we have here in the columns those different functions. I don't include here the day, month, and year functions because it's very similar to the date part. So here the first thing to understand is that the date part output gonna be a number, date name output gonna be string, date trunk output gonna be date and time. And we're gonna work with the same example. So we have the following information about the date and time. So now let's go and see the output of those functions and those different levels in the date part. So now let's start with the first level, the year. If you say, I would like to have the date part of this information, you will get 2025. The same thing for the date time, but this time for the date trunk, you're gonna reset everything below the year. So you will get the 1st of January 2025. So let's move to the next level. We have the quarter. The date part quarter of this date is going to be 3. The same for the date name, it's going to be 3. But this time it's interesting, right? Because in date time, we don't have usually the quarter informations. So this time it's going to reset to the first month of the quarter. It's going to be the month number 7. So let's move to the next one. We are at the month level. So if you use the date part, you will get 8. If you use the date name, you will get the full name of the month, August. And if you use the date trunk, you're gonna reset everything below the month and you will get the first day of August. Moving on to the date, if you use the date part, you will get a number 20. The date name, you will get a string value 20. And this time at the date trunk, you are resetting the whole time. Moving on to the next one, we have alternative for the day. And here we're gonna get the weekday, the number of day inside a week. So here we're gonna get the number 4 from the date part because it is Wednesday. So if you are using the date name, you will get the full name of the day, Wednesday. And for the date trunk, nothing gonna change. We're just gonna reset the time as well. And now if you are moving in details, if you extract the hour for the date part and date name, you will get 9. And here, as you can see, we are resetting now only the minute and the second because you are not interested in it. So moving on to the next one, minute, we will get 45 in date part, date name. And here we are resetting only the seconds. As you can see, only seconds are zeros. Now let's move to the lowest level in the hierarchy. We have the second. So we're gonna get 21, 21, and the output gonna be exactly the same value in the input. So with that, you can see the big picture using those 3 functions and what are the main differences between them and what you're gonna expect if you are using them. So now let's go back to Tableau and start practicing those functions. Okay, so now we're going to go to our big data source. Let's go to the orders and we will be manipulating the order date. So let's take it to the view. Tableau going to convert it immediately to a year. So we are not seeing the original data. We are seeing only the year part from the order date because Tableau wants always to make visualizations. And of course, it makes sense to have the years instead of all dates inside our data source. But in order now to show all the data like in our data source, we're going to go over here and switch it back to the exact date. So let's click on it and Tableau going to convert it to continuous, but I would like to see all values. So we're going to switch it to discrete. So now as you can see, we get all the values exactly like the source system. So we have around 5 years of data. So now we're going to go and practice by extracting the date parts. We're going to start with the year. So let's go and extract those years. We're going to go and create a new calculated field. Let's call it order date year. So here we have a lot of ways in order to get this information. We can use the date part, the date name, the date trunk, or even the year function. All right, so now we're going to start with the date part. And as you can see, it accepts 2 arguments, but the third one is optional. Here you can define what is the start of the week, but I usually leave it empty. So the date part that we want to extract now is the year. Then the date that we want to manipulate is the order date. So that's it, and as you can see that the calculation is valid. Let's go and hit OK. And as we learned, the output of the date part is going to be a number. That's why Tableau going to create a new continuous measure. But I would like in the visualizations to see is distinct values of the years. So I'm going to go and convert it to a dimension. So now as you can see, it jumps to the dimensions and we have it now as a discrete dimension. Let's bring it to the view and check the results. As we can see, now we have all the years extracted from the order date. So now let's go and try the other methods. Let's replace the date part with a date name. Here it's very important to understand that the data type gonna change. So here we have it as a number, and if we switch it to data name, we're gonna get it as a string. So let's go and change our calculation. Instead of date part, I'm gonna have date name. So let's hit apply, and as you can see, immediately the data type gonna switch to string value. But in the view, we're gonna get exactly the same result, right? So nothing gonna change, only the data type. Now we're gonna move to the easiest one. The quickest one is to use the year function. So instead of the whole thing over here, we're gonna write year, and we don't have to specify the date part. That's why we are getting an error. We need only our date that we want to modify. So that's it. Let's hit apply. As well, nothing gonna change in the view, but the data type gonna switch to number because the output of these functions is a number. So now you might ask me, okay, which one should I use? I recommend you always to use the quick one, of course, but what is more important is the data type. The data type number is always faster than the data type string. The data type string is the worst. It is the slowest data type from all others. So we always try to avoid the data type string in the visualizations, not to have bad performance in our views. So if you are thinking about those three functions, I would always avoid the date name. So now we are left with two functions, date part and the quick function. I would always go with the quick one, right? Because it's easier to write. So I would prefer in this situation to have year order date like I'm showing it in the view. But of course, in a lot of situations, you want to show, for example, the day name or the month name. So it depends really on the requirement, but if you can avoid it, don't use date name. So that's it. This is my recommendations to you and what I usually do. So now let's close this and extract another part from the dates. We're gonna have the quarter. So here again, we have the three options and all three deliver the same information. So I would go and create a new calculated field. Let's call it order dates, quarter, and this time I'm going to use as well the quick one. So quarter, order dates. So that's it. It's really simple, right? Let's hit OK. And now we have again a new continuous measure. I would like really Tableau here to create immediately a dimension. So I'm going to go and convert it again to dimension because I use it in the view as dimension. Let's check the results and we can see we have now the quarter number, which is correct. All right, so now let's go and extract another information from our dates. We're gonna get the month. So let's go and create again a new calculated field. We're gonna call it order dates month. And now this time we can use a month function and our field order dates. It's very simple, right? So let's go and hit OK. And we're gonna convert it again to dimension and bring it to the view. So with that, we are extracting the month information from the order date. So everything looks fine here. We have September, August, and that's it. And here we are usually in this situation where the users would like to see the months as a full name. So instead of having the month number, we would like to have the month's name, which I really agree because it's easier to read the month name than the number. So in order now to change it, we're going to use the date name function. So let's go and change our calculation. So let's go and edit. And now instead of month, I'm just going to remove it. Let's have the date name. Then the part going to be month. And then we have our order dates. So let's hit OK. And now, of course, what happened? We changed the data type and as well the values inside this field. So we are now getting the complete name of the month. So we have January, February, and so on. So that's it. This is how we can extract the different dates parts from our original field, the date. So now the question is how to use those new informations in our views. All right, so now we're going to go and create a view from three informations: category, order date, and sales, using a heat map or highlighted table. So now the first thing that I would like to do is to remove the order date. This is a lot of details. We don't need it in the view. Then we're going to have in the rows the year. I'm going to leave it, but I would take the quarter to the columns and as well the month. And of course, what is missing now is to fill those gaps using a measure. So our measure going to be the sales. So let's drag and drop it over here. So now in order to convert it to a heat map, we have to add it as a colors. So let's take the sales again and put it in the colors, or you can hold Control and drag it to the colors. We're going to get the same results. Now we are almost there. I would like to have, instead of text, I would like to have squares in order to get the heat map. So with that, we got a heat map. We can change the colors if you want. So let's go to colors, edit colors, and I would like to have it as blue. So hit OK. So with that, we have created our heat map using only one field, the order date. So we have the years from the order date, we have the months from the order date, and as well the quarter. So as you can see, those parts that we extract from the date are really useful to make visualizations. So now we can go and add the final touch in this view, and that is by making abbreviations from the month name. As you can see here, the February is really big for the cell over here, so we can make it shorter. In order to do that, we can use the lift function. So let's go to our calculated field and edit it. And now before, we're gonna add a left, and then at the end we're gonna add 3. So I would like to get only 3 characters from each month. Let's go and hit OK. Perfect. Now we have abbreviations for each month and the view look more professional. There is that thing that we have to add. I promise you the last one. It is the category. We forgot about it. So let's go to the categories and just drag it before the year. So with that, we got really nicely those categories, and we can see inside it how those categories are developing over the time. So with that, we got a really nice heat map with all those informations from the dates. Now we have in our data source a lot of new informations about the order date, where we can use it like almost everywhere. Now we have another very common use case for those new informations, where we can use those date parts as a filter. So let me show you what I mean. Let's go again to our orders and we're going to go to the month. So right click on it and show it as a filter. The same thing we're going to do for the year. So right click on it and as well show it as a filter. So now we can see those informations on the left side, and the logical order is very important. So first a year, then a month. And since the month has a lot of values, let's go and switch it to a drop down with multiple values. So now using those filters, the users can go and specify what is the scope for this view by changing the values of the year and as well for the month. So this is very common use case for the date parts in Tableau. So that's it for those functions. Now let's move to the last one. We have the data trunk. Okay, so now in order to see the effect of the date trunk, let's go to the big data source and get all the order dates to the view. I would like to see the exact date, so let's switch it to exact date and again to discrete to see the values. Alright, so next we're going to take the sales to the view as well. And with that you can see we are seeing all the days, all the information that we have inside the data source, and we have a lot of details. So now let's say that I'm not interested in the days, I would like to see one date for each month. So we would like to have this date at the month level. In order to do that, we're going to go and create a new calculated field and we're going to use the date trunk. So let's go and do that. We're going to call it order date and then trunk. So the syntax is going to be like this, date trunk, and it accepts two arguments. The first one is going to be the date part, which level we want to see in the view. So we want to have the month. So let's specify here month, then the date that we want to manipulate, which is the order date. So that's it, and the calculation is valid. Let's go and hit OK. And as you can see now on the left side, we got a new dimension with the data type date and time. So what we're going to do now, we're going to go and replace the order date with this new field. So just put it on top of it. And again, here we have to do the same thing. So right click on it, switch it to exact date, and then again to the discrete, and now we have a new date field where everything at the month level. So we have always the first of the month, so we have the 1st of January, the 1st of February, and so on. So as you can see now, the list is shorter, right? Because we have now one row for each month. Before we had one row for each day. So now I'm not interested in those zeros in the view. I would like to get rid of them. In order to do that, we can change the data type. So let's go to our date trunk and let's switch it from date and time to date. So let's go and do that. So as you can see now, we have a date field and all the time is away. So now let's say that I would like to have a date only at the year level. So I don't care about the days and the month. I would like to have one row for each year. So in order to do that, we're going to go and edit our calculated field. And now simply we're going to go and change the value from month to year. So that's it. Let's go and hit apply, and you're going to see over here that we have now one row for each year. So now we have a field always at the year level, and we got like around 5 years. So as you can see with the date trunk, we can control the level of the date field. So let's say that we want to switch it to day. So we're going to go and switch the year to day. And now with that, we're going to get all the details. We have one row for each date. And with that, we have a lot of details. So we are back like the original field, order date. So this is how we work with the date trunk in Tableau. Okay, so there is another way in order to visualize the effect of the date trunk. So let me show you how to do it. Let's first close this thing here, and then we're going to switch the order date trunk to continuous field. So let's go and do that. And now let's go and flip everything. So we're going to have the order date at the columns and the sum of sales at the rows. And instead of having bar, let's have a line. So now in the visualizations, we have a lot of marks. So if you mouse hover on those informations, you can see we have one mark for each day. And that's because we have defined in the order date trunk that we are at the day level. And you can see here on the details, we have around 1,800 marks in this one view. So now if you say this is a lot of details, let's switch it to month. So let's go to our calculated field, edit it, and just move it over here on top. So instead of day, we're gonna have a month. So let's go and hit apply. So let me just close this from here and let's check the view. We have now for each month one mark. So we are at the month level and the marks are totally reduced. Yeah, so we have only 60 instead of thousands of marks. So with this, we don't see a lot of details in the view. We have one mark for only 1 month. So this is the power of the date trunk. Let's say that we want to go to the years, and I think you know already how many marks we're gonna get. We're gonna get only 5 marks. So each point, each mark mark gonna represent a year. So this is the power of the date trunk to control your view and which details we are talking about. Alright, so that's it for those functions. They are really great in order to extract specific part from a date, and as you can see, they are really useful for the visualizations. So now we used a lot of calculated fields. As you can see on the left side, we have a lot of new dates in our data source, which is globally. That means if I go to any other worksheets or even to any other workbook connected to my data source, I'm gonna see the exact fields that I created using the calculated field, and I can go immediately and start reusing them in my visualization, which gonna save a lot of time by doing formatting and so on. So that's it, how to extract the dates parts using calculated fields to be globally. Next, we're gonna start talking about how to do it quickly locally for only one view by formatting the field. Okay, so now we're gonna start from the scratch. We're gonna go to our big data source. Let's go to the orders and get the original field of the order date to the columns, and again let's take the cells to the rows. Now as you can see, Tableau always brings it as a year, and that's because it wants to visual only small amount of data at the start, and then you decide on what you need. So here we can go and manipulate the order date directly in the view by changing the format instead of going and creating calculated fields. Now in order to format the date, we're gonna click on the dimension itself, so right click on it, and now we have here two important sections. So the first section is a discrete section where it's gonna use the function date part, and the other section is a continuous section where it's gonna use the date trunk. And here always on the right side, as you can see, we have those gray examples in order to show you which format gonna be presented in the visualizations. For example, there is no difference between this year and this year, but here you have the quarter Q2, but here we have the quarter plus the year. So you can see the formats that Tableau gonna use in the presentation, in the view. So now let's go and check the differences between this month and this one. So let's start with the first one. Let's click on month. So now as you can see, our field stays blue, so that means it's discrete, and we have those values, January, February, March, and so on. So we have it as a text. And if you would like to know how Tableau did create this, you can go over here on the month, double click on it, and you're gonna see the format. So Tableau he is using date part, month, then the order dates. So you can see the syntax that is Tableau is using to quickly format your view. So now let's go to the next one. We're gonna have the month as a continuous field. So right click on it again, and now we're gonna have the month plus the year. So let's go and click. Now you see that our field is continuous, and if you double click on it, you can see that Tableau is using date trunk. So now we see the years in the axis, and each mark, each point of those stuff are a month. So as you can see, it's very easy. We are just clicking around and we are changing the whole format of our dates. So what I usually do, I go and select different formats until I'm convinced about the correct format that's gonna represent my data. And there are as well a lot of different formats. So let me show you. Let's go to the order date. And as you can see, we have, the year, quarter, month, but here we have the option of more. You can see we have a week number, a weekday, and you get more options if you go to the custom. Now here you're gonna get a list of all possible formats that we can use in order to change the structure of our date. The same thing, of course, for the continuous field. So if you go again to the continuous, you can see we have here as well more. So you click the custom, and as well you can change the different formats. And of course, any decision that you are making now in the view, it's gonna stay only in this view. So if you switch to any other worksheets, you will not find what you have already formatted. So this is the only disadvantage of making a lot of decisions in one sheet, then you will not have it in the next sheets. And there is as well more options on how to format the fields. For example, let's go to the order date, right click on it, and let's choose this month as a full name. Then I'm just gonna switch those columns with the rows. Now you can see that in the header we have the full name of the month, but we can go and change the format of those headers by just right click on it and then go to format, and then on the left side we can change the display format of the header. So for example, on this one, on the dates, if you click on it, you will get different options, like here, for example, the abbreviation. So once you click on it, you can see now we have an abbreviations of the month name, or we can get the first letter of each month if we want really to make it small. So we can go over here and change it to first month. With that, we're gonna get the first character of each month. And of course, those formats are not only for the month. Let's take, for example, the weekday. So we're going to go over here, then switch it to weekday. We have here the full text of the day. So in order to make it abbreviations, we're going to go on the left side again and switch it to abbreviation. And with that, we're going to get a shortcut for the weekday. So as you can see, by just clicking around, we're going to change and manipulate the values of the dates inside our data source without writing anything, without writing any syntax or creating new calculated fields. So we can just do it quickly in one view. But here, if you find yourself that you are repeating the same format over and over in different sheets, I recommend you to go and create a new calculated field for that to store it at the data source and use it once you need. Alright guys, so that's it for those functions and how to format the dates. Okay guys, so with that we have learned how to extract a specific date part from our date field. Next we're going to talk about two functions, date add and date diff. Okay, so now we're going to learn how to add and subtract dates in Tableau using the two functions date add and date diff. But as usual, let's understand the concept, then we're going to practice. Alright, so now we're going to talk about the function date add. We can use it in order to do mathematical operations on our date field. So for example, we can add 3 days to our dates, or we can subtract, for example, 2 months from our date. So we can manipulate our dates by adding or subtracting specific intervals from our date. So now let's see the syntax in Tableau and take some examples in order to understand it. So it starts with the date add as a keyword, then it needs 3 arguments. First, the date part that we are interested to manipulate. The interval is like how many days, how many months you want to add. Then we have the date field itself that we want to change. The output, the result, going to be a date field. So for example, let's say that we want to add 3 years to our date. So we specify at the date part years, then the interval going to be 3, and then our date. So what's going to happen? Tableau going to go and add 3 years to our date field. So with that, we are adding 3 years to this piece of information, the year, and the rest, the months and the days, going to stay as it is. So let's move on. Let's say that we want to add 3 months instead of 3 years. So what we're going to do, we're going to specify a month at the date part, then 3 as an interval, then our date as well. So what's going to happen? We're going to change only this piece of information. So instead of having August, we're going to have November. So with that, we are changing only the month. The rest going to stay as it is. And now we're going to move to the last one, to the day. We would like to add 3 days. I think you already got it. So what's going to happen? We are going to add 3 days. So we're going to have the 23 instead of 20, and it's changed only at the day level. The rest going to stay the same. So with this, you can see we can add different intervals to different date parts in our date field. And in our examples, we were working with positive numbers, but in Tableau, we can as well use the negative numbers. So with that, we're going to subtract the intervals from the date. So let's take an example. Let's say that we want to subtract 3 years from our date. So we're going to have here the interval as a -3, so -3, and the output we will have, instead of the year 2025, we will get 2022. Of course, the same thing we can do it on the day. So we would like to subtract 3 days from our date. So instead of having the day 20, we're going to have 17. So as you can see, we can use the date add in order to add new intervals, but as well to subtract intervals. It's a very important function in Tableau in order to compare things together. Like we can compare this year with the next year. So we're going to go and add 1 year to our field. And with that, we're going to get 2 fields, the field with the current year and the field with a next year. We will see that in next examples. So that's it for the date add. Let's move on to the date diff. The date diff function in Tableau has a very simple task, and that is to subtract 2 different dates. So for example, let's say that we have 2 dates, the order date and the shipping date in our data source. So let's say that you ordered something in this date, 2025 in November, and you received your order in the next day in February. So now if I ask you how long it took to ship your products to your house, you're going to subtract those 2 dates in order to give me the number. And this is exactly what the date diff does in Tableau. So the syntax is going to be looking like this: date diff, then we have 3 informations, which date of birth you would like to subtract, then we have the starting date, in this example the order date, and then the end date, the shipping date. The output going to be always a number. So as usual, we're going to have examples in order to understand it. So here we're going to ask Tableau how many years it took to deliver, to ship this product. So here we are interested in how many years. We are interested in the year part, then the start date going to be the order date, and the end date going to be the shipping date. If you do that in Tableau, you're going to get 1. So it took 1 year to ship the product. So here we are talking at the year level. You will get 1. Now let's go to the next level. Let's say how many months does it take to do the shipment. So here we are specifying at the date part a month. We have as well the same informations for the start and the end date. And this time you're gonna get 3 months. So the answer gonna be it took 3 months to ship the product to the customers. Alright, the next question gonna be how many days it take to ship the product to the customers, and this time it's gonna be 68. So now we are talking at the day levels. So the result gonna be it took 68 days to ship the product from the order date to the shipping date. So in this situation it makes sense to use the date because we always want to understand how many days exactly it took to send the product to the customers, because if you have like a year, you're gonna think it took the whole year to send the shipment. So that's it. This is how this function works. It's very simple and very useful in the visualizations. So now let's go back to Tableau and start practicing those two functions. Alright, so now let's go and see how we can create that in Tableau. We're gonna stay at the big data source. Let's go to the orders and we're gonna manipulate the order dates. So let's bring it to the view over here and we're gonna show the exact date. So we're gonna go and switch it to exact date to see all details, and I would like to have it as discrete to see all the values inside our data source. So now it's really simple. Let's say that I would like to add 1 year to my order date. In order to do that, we're gonna go and create a new calculated field. So we're gonna call it order date plus 1 year. So we're gonna use the function date add, and it needs 3 arguments. The date part, so we are adding 1 year. So the date part gonna be a year. The interval gonna be 1, and the date that should be manipulated is the order date. It's very simple. So as you can see that Tableau says the calculation is valid. Let's hit OK and check the result. So as you can see, we got a new field in our data source with the data type date and time. Let's check the results. We're gonna grab it to the view, but I would like to see as well the details. So I would like to see the exact date, and again we have to switch it to discrete in order to see the results. So let's switch it to discrete. And now as you can see, we have a date and time. If you want to get rid of the time, we can cast the field to date. So in order to do that, let's go to our data pane. So this is our field. Click on the icon of the data type and switch it from date and time to date. So let's do that. And as you can see now, the time did disappear. And as a result, we see that everything is plus 1 year. So we have here 2018, at the result 2019. So we can check other dates. If we sort this as descending, we can see that we have the value as 22 and here we have it as 2023. So that's it. This is how we can create a new field with plus 1 year. Let's add 1 month. So now let's go and edit our new calculated field. So right click, edit, and let's change as well the name from year to month. And now instead of the date part year, we can have month. So it's very easy to switch, and if you select apply, so now we can see that we are adding 1 month to the data. So if I sort it again to the old one, you can see here we have January, and now we have it as February. We can do the same if you switch it to day, if you want to add only 1 day. So let's apply, and as a result, you can see that we are adding everywhere plus 1 day. So of course we can add to the intervals negative numbers. So let's say we would like to have minus 1 day. Let's hit apply and check the results. So as we can see in the results in the new calculated field, it's always 1 day behind the original field of the order dates. So that's it. This is how we can work with the date adds. It's very simple. Alright, so now we're gonna go and create a new view to analyze the average days to ship per subcategory. It's very important for inventory management, optimizing operations, allocations of resources, and so on. So we're gonna create that using the date diff in Tableau. But first, let's bring a lot of data to the view in order to understand how this works. We're gonna stay with the big data source. Let's go to the orders, and here we need our 2 dates. The first one gonna be the order date, and the second gonna be the shipping date. And let's add as well the order ID at the front. Yeah, we're gonna add everything to see the result. And as usual, Tableau show it as a year. We would like to see all the details. That's why we're gonna go and convert it to exact date. So for the first one, we're gonna do it exact date. It might take a little bit long time because we have a lot of data, and we have it now as a continuous. I would like to see all distinct values. So let's convert it to discrete and do the same thing for the shipping date. So we're going to convert it as well to exact dates and then to discrete. So we're going to go and move it to discrete. Alright, so now we have all the information that we need. So we have for each order 1 row. Now we're going to go and create our new calculated field in order to find the differences between the order date and the shipping date. So let's go and do that. We're going to go and create a new calculated field called days to ship. And we're going to use the function date diff, and it needs 3 arguments. The first one is the date part. Here, of course, since we are saying days to ship, we are interested on the days, how many days it took to place the shipment at the users. So we're gonna enter here day. The start date is gonna be, of course, the order date, and the end date is gonna be the shipping date. So we have it like this, and let's check the validation. The calculation is valid, everything is fine. Let's go and hit OK. And since the output gonna be a number, Tableau did create it as continuous measure. So let's take it and put it on our view and check the results. So let's take, for example, this order. The customer did order in December the 7th, and after 4 days, the customer did receive the shipment. So with that, you can see the differences between those 2 days is 4 days. So everything looks good. Let's take another value, maybe some recent orders. So I'm gonna sort it descending from the order date, and as you can see here, the customers did place an order at the last day of 2022, and after 24 days did the customer receive the shipments. So we can see here the days to ship is 24. So this is how the date diff works. Now we're gonna go and create our visual. So we want to show the average days to ship per category. So now we want to get rid of all those details, we don't need them, and we just need our measure. So now we need the subcategory. Let's go to the product and get the subcategory over here, and then we're gonna take our measure and put it on the columns. But now we have it as a sum, we would like to have it as an average. So click on the measure, then go to the measure sum, and here we have the average. So let's switch it to that, and now we're gonna add some more informations. Let's add a label, and as well let's change the colors. So let's bring the average days to ship, control, and then put it on the colors. And since it's bad thing, we're gonna switch the colors to red. So let's go to the colors over here, edit colors, and now instead of automatic, we're gonna switch it to red. All right, let's click OK, and then we're gonna go and sort the list like this. So now let's go and check the data. As you can see, the worst subcategory we have in our data is the copiers. It takes longer time to be delivered to the customers compared to the other subcategories. So now the question is, we have 5 years of data inside our data source. Was it always like this, that the copiers was the worst, or something changed with the time? So now in order to compare the years, we're gonna add the years to the view in order to compare those informations. So we have already the year prepared from the last time, so we have the order date here. Let's just bring it to the view to the columns. So now if you check the data, it's very interesting. If you focus on the copiers again, you can see that in 2018-2019, the performance was really good. Even it was one of the best performance in 2019. It gets this light red. But something changed, yeah, in 2020. So from 2020 and forward, you can see it's always dark red. So there is like change in maybe the resources or in the inventory management. We can see it is one of the worst performance compared to the other subcategories. So with that, you can compare the years as well together to understand whether it was always like this or something changed. So as you can see, using the visualizations, the coloring, and as well those functions that we have in Tableau to manipulate the dates, we can uncover like those trends inside our data. Maybe it's really hard to find it from the raw data, right? But if you bring everything with colors and everything in the visualizations, it's gonna be really easy to detect. So this is exactly the power of visualizations and those functions. Alright everyone, so with that we have learned how to add and subtract dates in Tableau. Next we're gonna talk about two functions, today and now. Okay, so now we're gonna learn about two cool functions in Tableau, today and now, in order to get the current date or the current date and time. So let's go. Alright guys, so one of the very famous use case of the today function in Tableau is to make something like this. You can make highlight in the visualizations about the current date in the view. So we can see here like a separator in the visualizations with the current date of today. And with that, you can draw the attentions of the users by highlighting one of those parts. So now let's go and understand quickly what is today function. Alright, so we have those two functions, today and now. They are the easiest and the simplest functions in Tableau that will not manipulate or transform anything. There is no concept behind them. They will just deliver for you the current date and time informations as you execute them. So for example, we have the first one, that today. It does not need any argument. As you can see, it's very simple. The output can be a date, so you will get the current date informations. Now we are I'm recording at the end of May 2023, but if you are interested to have as well the time information, you have to execute now. No argument inside it. You will get date and time. So as I'm recording, it is 6 p.m, 10 minutes and 40 seconds. So that's it. So this is about the two functions. Let's go back to Tableau and start practicing when do you use them. Alright, so now we're going to see how we can use today function in our visualization. So the first thing is to create the calculated field. So let's go and create a new one and we call it today. Then we need the function that's called today as well. As you can see, it's very easy. We don't need to add anything else. And by the way, this is always the first calculation that I always create in each new data source. So without knowing the requirement or anything, I just go and create this one because I'm sure that I end up using this function. So it's really one of the first things that I usually do for each new data source. So let's go and hit OK. Everything is fine. So as you can see, we got it on the left side as a new dimension with the data type date. Let's check the current information. So we can bring it to the view. Tableau gonna convert it to years. So I have always to switch it to exact date and then to discrete in order to see the value. And as you can see, we are at the end of May 2023. So now it's very interesting in which year you are now checking the video and following me in those steps. Okay, so this is how you can create the today function in Tableau. Now we're going to use it in a reference line in one view in order to show you how powerful is this function. And we're going to create a view about the number of orders over the shipping date. So let's go and create it. I'm going to remove the today from here, and then we're going to add the shipping date from the orders, the columns, and then let's take the number of orders, the orders counts. Let's take it to the rows. And now instead of having the years, I would like to have months. So I'm going to do now a quick format. So let's go to the field and then we're going to go and pick this one, month. So let's click on it and the visualization type look as well good. So now let's go and create a new reference line. In order to do that, we're going to go to the axis over here, right click on it, and then we have here the option of add reference line. Here the most important thing to customize is the value of the reference line. I would like to have the value of today as a reference line to indicate the current information, the current date. But if you go to the values over here, you will see that I can either create a new parameter or I can use only the shipping date. And that's because our new field today is not yet in the visual. So we have to add it to the visual. In order to do that, we can close this first, and then we take the today and drag and drop it in the details. But we are not there yet because Tableau did convert it to a year. And I would like to have in the reference line the exact date of today. So in order to do that, we're going to convert it to exact date, right click on it, and we have here the option exact date. So that's it. This is the requirement to add it in the reference line. Let's go and add again the reference line and we go to the values. Let's check. Yeah, we got the today value. So let's select it and then hit OK. So now here on the right side, we got a very nice reference line indicating of the day of to date. But still there's like a problem, right? Because all of the data is behind the reference line because the data is a little bit old. So now in order to make it more interesting, I'm going to add 2 years to the shipping date to make the visual look better. So in order to do that, as we learned before, we're going to go and create a new calculated field. Let's call it shipping dates plus 2 years. And here we're going to add date add. First, we need the date part. So we are saying plus 2 years. We are talking about years. The interval going to be 2 and the date going to be the shipping date. Alright, so with that, we are done. The calculation is valid. Let's click OK. So we have it now on the left side. And what we're going to do, we're going to replace it with the old value. So let's just remove the old shipping date and get the new one to the rows. We're going to do the same steps. So we're going to convert it again to month. Let's do that. And now, as you can see, we have values for 2024, 2025. So let's add again the reference line, right click on the axis, add reference line, and let's go to the values and let's select it today. So now we got a very nice cut in our visual in between our data to show the past, today, and the future. So now we can go and add a little bit customizations just to make it look better. So for example, as you can see, we have a label over here for the reference line. It says minimum today. I would like to show immediately the value of the current date. In order to do that, right click on the line and then go to edit. And then we have to change the label over here. So instead of the computation, let's change it to the value. And with that, as you can see on the right side, we get immediately the current value of today. The next step, I would like to add some coloring to the reference line. So right click on the reference line and let's go to format. Then we have here 3 informations to customize. The first one is the line itself, then fill above, that means all the informations on the right side, fill below going to be all information on the left side. So for example, let's start with the line. I would like it to have it dotted and as well red The opacity, I'm just gonna make it to the 100. So now the next value is gonna be the fill above. I would like to highlight it with green. So let's go and pick the color green over here. And then the next one gonna be the below. You can leave it like white or you can make it like gray in order to show this is history. So with that, as you can see, the visual gonna look more professional. So we are highlighting the future and the history is like grayed out. So that's it. With a small function in Tableau like the today function, you can create amazing dashboard and visuals for your users. And this is one of the most common use case of the today function in Tableau to highlight the data. Okay everyone, so that's it for today and now functions. With that, we have learned all the use cases for the date functions in Tableau. We have covered around 10 functions in Tableau. Next, we're gonna jump to the next group. We're gonna learn about the null functions. Okay, so now we're gonna focus on another group of functions under the category row level calculations, the null functions. The main purpose of the null functions in Tableau is to handle and manipulate the missing values in our data, the nulls. We can have missing values like everywhere, in text, dates, numbers, any field in our data source can have like missing values. So why handling the missing values, handling the nulls is a very important step in the analysis, and that's because of two things. First, the calculation accuracy. Null values can affect the calculations and the aggregations in the results. So if we have null values in our data and we ignore it, we don't do anything about it, what's gonna happen? We're gonna have incorrect calculations and corrupt results. The second reason is to improve the data quality and to achieve completeness. Identifying the data gap, the wrong in the data entry, and having issues in the data collection can help the overall data quality in our data and can improve as well the completeness in the data visualizations. So that's why the null functions in Tableau are very important to have accurate and correct analysis in the data visualizations. So as usual, let's understand the concept, then we're gonna practice. Let's go. Okay, so now let's go and understand those three functions, zn, ifnull, isNull, in order to handle our missing values. As usual, we're going to go with the example because it is the best way to understand those functions. Alright, so now we're going to have 4 customers and their sales. As you can see, only Maria has a missing value in the sales. So we have here a null. In order to handle this null, we have the first function in Tableau, the zn. Zn stands for 0 nulls. It can replace the null values with 0. So it's very simple. If you use now the zn function for the sales, for the first value we will not change anything, right? We will get exactly the same value, but for the next one, since it's a null, it's gonna replace it automatically with a 0. The next 2 customers we will get exact values because they are not nulls. So as you can see, very simple, we are just replacing the null values with a 0. So this is a very quick way to replace the nulls. But here the problem is we have no control what we are replacing. So here we cannot specify something else. We will always get a 0. In order now to specify our value, we can use the second function that we have in Tableau, ifNull. ifNull, it can replace the null value with a specific value from us. So if you use this function on the sales, it can has the following syntax. It needs 2 arguments. The value that we want to manipulate and the value that we specify. So in this example, I'm going to specify it as 0. It doesn't make sense because we can use zn, but just to show you that we're going to get the same results. So you can go over here and put anything you want. So for the first customer, we're going to get exactly the same results. For the second customer, we're going to get again a 0 because we specified that. We have the control on that. And then for the last 2 customers, we're going to get exact results. And here the output is a number because the field that we want to manipulate is a number. But let's say that we take another field which is a string, the output gonna be as well a string. So here is exactly the difference between zn and ifnull. Zn accepts only numbers, but the ifnull accepts any field from your data source. So for example, let's say that we have the countries. So John has no value in the country. Same for Martin. We have only for Maria and George informations inside the field country. Here we cannot go and use the zn function because it's not number, it's string. So in order to manipulate those values or to replace the null values, we're gonna go and use the ifnull. So the syntax is gonna look like this. If null country, then we have the abbreviation of not applicable. So the output here gonna be a string value. For the first customers, we're gonna replace the null with in A. The next one is going to stay the same because there is nothing to replace. The third one we're going to get as well, not applicable. And for the last one, we will get France. So nothing to be changed. So this is exactly the differences between the if null function and the zn function in Tableau. Now we're going to go to the last function, is null. Sometimes we might be in a situation where we want to check whether the field has null values or not. So we don't want to do any actions yet. We are just checking, right? So the is null in Tableau going to return true if the value is null and false otherwise. So that means if there is no value, if we have missing value, we're going to get true. If there is a value, we will get false. So the output of this function going to be with the data type boolean with only two values, either true or false. So let's check the example or the syntax in Tableau. It's going to accept only one argument, the country, and that's it. So the question for the first customer, is it a null? Yes, it's null, so that's why we're going to get true. For the next customer, is it null in the country? Well, no, so we're going to get false. The same for the third one, we're going to get true. And the last one, we're going to get false because we have a value in the country. So that's it for the is null. So we have three functions, three tools to manipulate or to check the null values inside our fields. And they are really useful to improve the quality and the completeness of your visualizations. So now let's go back to Tableau and start practicing them. Okay, so this time we're going to go to the small data source. Let's check the orders information. So we're going to take the order ID and we're going to take this time the profit. So drag and drop the profits on the ABC over here to see the values. And now if you check our data, you can see that the order 7 don't have any profit informations, and as well the order 10 don't have anything. So we have here missing data, we have nulls. So now let's do something about it and fix it. Instead of having null, we have to have zeros. So here we have two functions to do it. Let's start with the first one, the zn 0 nulls. So now we're going to fix it and create a new calculated field. We're going to call it profit zn, and the syntax starts with the function zn, and it needs only one argument, the field that we need to fix. So it's going to be the profits. So that's it. With that, we are changing all the null values to 0. So again, here in this function, we don't have control to change the value to something else. It's going to be always 0. So the calculation is valid. Everything is nice. Let's click OK. And as usual, we're going to get a new measure since the output is going to be as well the profit informations. So drag and drop this new information to the view. And now we can see on the results, all those values going to stay the same. Only we are manipulating the nulls. So we are replacing the nulls with a 0. Here as well, for the order number 10, we have null. Now we have a 0. So it's really easy and quick fix. Alright, so now you might say, you know what, why we are making all those efforts to replace those missing values with 0? So what is the big deal? I could just leave it as a null and the users might accept it. So why we are doing this? Well, it's not only the visual going to be better, but also having missing values going to bring wrong and inaccurate aggregations. So let me show you what I mean. Let's just remove the order ID away. And now you can say, okay, we got the same numbers, right? We got the same aggregation, so everything is accurate and fine. Well, not exactly. This is only for the sum. So now let's go and switch them both to the average. So we're going to go over here and switch it to average, and we're going to do the same for the corrected one. So now I'm going to just make the headers a little bit wider to see the values. So now as you can see, now we are getting different values. So with the zn function, we got different average from the original data. And that's because in this average, we are not counting the orders with the missing values. With the zn, we are counting now the orders with the missing values. So that means replacing the missing values with zeros, we will get accurate results at the average in the aggregations compared to the old one. So that's exactly why we go and replace the missing values with zeros, especially for aggregations and calculations. Alright, so that's why we do it. Now let's go and try another function. We're going to use the if null in order to replace the null values with zeros. And now I'm going to just bring the order ID to the view to see all the orders. Let's go and create the new calculated field. And we're going to call it profit if null, and the syntax starts with if null, and it needs two informations. The first one going to be the field that we want to manipulate, so it's going to be the profit again. And for the next information, we have to specify which value going to replace the null. So in this example, we're going to stay with the 0. So the calculation is valid. Let's hit OK. And we got again our new calculated field. Let's bring it to the view and check the results. As you can see, it is identical to the zn. So for the order number 7, instead of null, we got 0. The same for the 10, we got as well 0. So in this situation, if we want to replace it with zeros, I would go with the zn since it's just faster to write it. So now let's move to the next scenario where we want to replace the nulls with the the value 1. So this time we cannot use the ZN because ZN can automatically convert it to 0. We're going to stick with the if null. So let's go and edit our calculation. And instead of 0 here, we're going to specify 1. So let's go and hit OK. And now we can see instead of having 0, we have the value 1. So instead of null, we have 1. So this is the advantage of the if null. We can control which value can be the replacement for the null. Alright, the next advantage of the if null is that we can replace not only number values, we can replace as well any other data type. So let's take an example. We're going to go to the customers and let's get the customer email to the view. And as you can see here, we have some nulls. We don't have all the emails from all customers, but now the task is to replace those nulls with unknown. So let's go and create a new calculated field in order to replace those values. Let's call it customer email if null, and the syntax again, if null. It accepts 2 arguments. The field that we want to manipulate, it's going to be the customer email. So this one over here, and which value we're going to use in order to replace the nulls, it's going to be the unknown. So that's it. The calculation is valid. So we're going to replace all the nulls with this value. So let's go and hit OK. And now we have again here a new dimension in our data source. Let's grab it to the view and check the values. So now if you just compare those 2 columns, you can see instead of null, we are getting unknown. The same here and the third one over here, and the others will not be affected because we have a value inside the field. So as you can see, it's really nice and quick way to replace those bad nulls in the view. So that's all for the if null. Now let's check the last one. We have the is null. So the is null will not replace the values with anything, it's just to check whether there is a null or not. So let's say that we want to check whether in the field profit we have any nulls. In order to do that, we're going to go and create again a new calculated field. Let's call it a profit is null. And the syntax for that is very easy. So is null, and it accepts only 1 argument. It's going to be the field that we want to check. So we are checking the field of profit. So the calculation is valid, and that's it. It's really simple. We are checking whether this field contains any nulls inside it. So the output can be either true or false. So it's going to be a Boolean. So let's hit OK. And now as you can see on the left side, we have a new field with the data type Boolean because we have only true and false. Let's drag and put it on the view over here. And here we can see quickly all those orders is a false because we have a value inside the profit. But here we have a null. That's why we are getting true. And here again, we have a true. So with that, we can check immediately whether we have nulls inside our data or not. So let's go and show it as a filter. This is what I usually do. So if I see there is true, I'm interested to see those values. So I can see, all right, we have 2 orders where we have nulls inside the value profit. So this is really quick way in order to check whether we have any problems, any nulls inside our fields in order to make a plan what we're going to do about it. But here in the small data source, it's really easy to see individual, like all the orders. We have only 10 orders, but imagine you have thousands or millions of orders inside your data. Individual, it can be really hard to see. So let's take an example in the big data source. So we're going to go over here, take again the order ID, and as well, let's check this time the sales. So drag and drop it in the view. As you can see, it's really hard to check now in the view whether we have nulls or not. So instead of that, we can do a check. So we're going to go and create a new calculated field. Let's call it sales is null. And now we can use the function is null. This time the field going to be sales. So we are checking the sales. So let's go and hit OK. And now we're going to show this field as a filter. So now in the filter, we can see immediately that we have only 1 value, false. So we don't have true. That means we don't have any nulls inside our data. So this is a very quick check inside our data to see whether there are nulls instead of just like scrolling down and checking all the orders. That's why we need the is null function. So with that, we have covered all the 3 functions that deal and handles with the null. This is very important to improve the quality of your visualizations and to bring accurate data in the aggregations. Alright, so with that, we have covered everything about how to handle the missing value, the nulls in Tableau. Next, we're going to move to another group of functions, the logical functions. Okay, so now we're going to talk about the last group of functions under the category row level calculations in Tableau. We have the logical functions. The main purpose of the logical functions in Tableau is to make logical decisions based on conditions. And here we have 2 use cases. The first group is the conditional operations. Here we have like if, else if, case when, and so on. The main focus here is to create conditional logics and make decisions based on those conditions in order to manipulate the data. And the second group is the logical operators. Here we have 3 operators and or not. And the main purpose of this group is to evaluate and to combine multiple conditions in Tableau. So now let's go and focus on the first group, the conditional operations. And as usual, first we have to understand the concept behind them, then we can practice in Tableau. So let's go. Alright everyone, so now we're gonna do a deep dive in those logical functions in order to understand how they work and how they're gonna be executed. And now we're gonna start with the simplest form of the if statement, where we have only one condition. And in this example, the condition gonna be if the sales is higher than 1000, then we want the value high. Otherwise, we end, nothing gonna happen. And now let's see the flow chart on how this gonna be executed. So we start first with checking the condition. Here we have always two ways, either false or true. If the condition is fulfilled, if the sales is higher than 1000, then we go this path where we're gonna have the value high. So if it's true, we're gonna get the value high and then everything ends. The other path, if the sales is not higher than 1000, then it's false, then we're gonna skip everything. So that means nothing gonna happen. Let's have the following example. Let's say that the sales has the value 1200. So now first we're gonna check the condition. Is the sales is higher than 1000? Well, yes, it's true. So what can happen? We can execute the high and it's gonna jump to the end. And if we are looking to the chart over here, first we are asking the question, is the sales higher than 1000? The answer is gonna be true. So we are taking the green path. This one where we can execute the high. Let's take another example where the sales equals to 700. So we start over here again. We ask the question, is the sales higher than 1000? This time it's not true. So it does not fulfill the condition and we're gonna go with the path on the right side. So what's gonna happen? Nothing gonna happen. The high value will not be executed and in the output we're gonna get the value null because there is nothing gonna be executed. So it's really simple, right? You are asking always the question that could be answered with yes or no, true and false. You have always two paths for each condition. So this is the simplest form of the if statement. Let's move to the next level where we're gonna have if-else statements. So now we're gonna stay with the same condition. If it is fulfilled, then we're gonna get the value high. But let's say this time, if it is not fulfilled, it is false, I would like to get a value instead of null. So here we can add the keyword else. So what we're going to do, we're going to add between if and end an else statement to say, okay, if it is not fulfilled, give me the value low. So let's check the flowchart, how it's going to look like. We start first with checking the condition. If it is true, the first path, we have the value high, but if it is not true, this time, instead of just jumping immediately to the end, I would like to get the value low using the else. So that means the output of the if-else statement is going to be always a value, either high or low. We will never get a null. So let's take an example. Let's say that the sales is 1200. It's going to fulfill our condition. So we're going to get the value high and the program gonna end. On the right side as well, the same thing. What's gonna happen? We're gonna check the condition, and since it's true, we're gonna get the value high and the program ends. The output gonna be the value high. So here it's like the last one, but now if the sales equals to 700, the condition is not fulfilled, and now instead of jumping immediately to the end, it's gonna jump to the else statement. So now let's check another value where the sales equals to 700. The condition will be not fulfilled, so it's gonna fail because the sales is not higher than 1000. So what can happen this time? We're gonna execute the else statement. We will not jump immediately to the end, so we're gonna go to the else and then we're gonna execute the else. So in the chart, we checked the condition and we took the right path where it is false. So now once we are at the else statement, it's not like the if. Here we will not have any condition. We have only one path. So we're gonna execute the low and the program gonna exit. So what's gonna happen? We will just get the value low and we end. So the output gonna be the low value instead of having nulls. So else will be always executed if the conditions are not fulfilled. So that's it for the else statements. It's very simple. Now we're gonna go to the next level where we want to add multiple conditions in our statements. Alright, so now we're going to talk about the else if statements. We can use it in order to add multiple conditions to our statements. So far in the previous examples, we worked only with one condition. We are checking whether the sales is higher than 1000. And if we are using the if-else statements, we're gonna get either high or low. Let's say that we want to introduce another condition in our statements to get the value of medium. So now we would like to add a new condition between if and else exactly after the if statement, but now we cannot go and use if again as a keyword. Instead of that, anything after the if, we can start using the else if statement to add more conditions. So for example, we can add the following condition in between. It's called else if the sales is higher than 500, then we're going to get the value medium. So that means in the whole statements, we can have only one if and only one else, but we can have multiple else if in between if we want to add multiple conditions. So now let's see how the workflow gonna look like. We start as usual with the first condition in the if statements. If it is true, what's gonna happen? We're gonna get the value high and everything gonna end. So now if that condition is not fulfilled in the first if, we're gonna jump to another condition in the else if. So here we have another condition where we're gonna check if the sales is higher than 500. And here we have again two ways out of this. Either it's gonna be true, either it's gonna be fulfilled. So what can happen? We're gonna get the value medium and then ends. And the other one, if the condition is as well not fulfilled, then we're gonna go and execute the else statements. So as usual, the else statement does not have any condition. It's gonna just execute the value and ends. Let's see a few examples in order to understand how this works. The first one gonna be the sales equals to 1,200. We are checking now the if condition. As you can see, it's gonna be fulfilled. We're gonna get the value high, and that's it. So what's gonna happen? We're just gonna skip everything to the end. If we are checking the workflow, so we're gonna check the first condition, and we will take this pass. So everything else gonna be ignored and will not be executed. We will just get the value high at the output. Alright, so now let's take another value. The sales equals to 700. So we are at the first condition, it will fail. So we will not get the high value. Instead of that, we're gonna jump to the next else if statement. So we are now at the right path. The true path gonna be deactivated. So we have here again another check. So we are checking, is the sales higher than 500? Well, this time it's gonna be fulfilled. So what's gonna happen? We're gonna get the value medium, and then the program gonna skip. So with that, we are at this path where we got the value medium as an output. So this means again that the else statement will not be executed. Alright, moving on to the next example where the sales equals to 350. Again, we are at the first check. 350 is not higher than 1000. That's why this is gonna fail. Then we're gonna jump to the next one to check whether it's gonna fulfill this condition. And the sales is as well here not higher than 500. So this gonna fail as well. So since now both of them are failing, what can happen? We're gonna go to the default. The default value is the else. So this gonna jump to the else, and we will get the low value from our statements, and this is going to be executed. Let's check the right side on the workflow. As you can see, we are the first condition, it failed. We go to the second one, it failed as well. Then we go to the last option that we have, to the else statements. We will get the value of low. So that's all about the else if statements. If you have a third condition, you just can add it after the else if or before it. So with that, you can add multiple conditions to your statements, and understanding the logical workflow behind those statements is very important to understand those functions. So all what you are doing here is we are evaluating different conditions, and based on the evaluations, we will get in the output different values. In this example, we have three possible values: high, medium, and low. Alright, the case when statement. It is very similar to the if statement. Here we're gonna evaluate as well multiple logical conditions, and based on our evaluation, we will get an output value. So let's take an example in order to understand the syntax. It starts always with case, then the field that we want to evaluate. So now we're gonna go and evaluate the values inside the country. So the first condition is gonna be like this. We're gonna write when. Then if the value is Germany inside the country, then the output gonna be DE. Here we are trying to make, like in the output, abbreviations from the countries. Now we're gonna go and make another condition for another value inside this dimension. So we're gonna evaluate the value France. If it is equal to France, then the output gonna be FR. Then moving on to the next condition, we're gonna evaluate the USA value inside this dimension. If it is equal to this value, then the output should be US. So as you can see, using the case when we are evaluating the members or the values of a dimension. So here we are evaluating like so here in those conditions, we are evaluating a scenario. So what can happen if the value of the country is Germany, and so on. So far we have three conditions, and if you are done and you would like to have a default value if none of those conditions are fulfilled. So if the value of the country does not fulfill those three conditions, what can happen? We're gonna go and execute the else statements, and at the end we're gonna have as well an end. So as you can see, it's really simple and easy to read, and as well easy to write. Alright, so now let's go and have an example in order to understand how the execution can be done. So let's say that we have the Germany value inside the country. So now as the code gonna be executed, we're gonna start from top to bottom. So that means we're gonna first evaluate the first first one, it's going to be when Germany, then DE. So as the values are matching, we will get the value DE at the output. And the code going to skip everything else. So we will not check France, USA, and so on. So the code going to go to the end, and as output, we're going to get DE. It is very similar to the if else statement, right? So let's take another example where we have France in the country. So here we start moving from the top to down. So again, the first condition can be checked when Germany, then DE. This time we don't have a match. So here we have France and here Germany. So it's gonna fail. We will get false. That means what's gonna happen? We're gonna jump to the next condition to check and evaluate the next value. So here we're gonna check again when the value is France, then FR. This time we have a match, so we will get a true. And with that, the application gonna like skip the other conditions to the end. So that means in the result we're gonna see FR. So now let's move to the last example where we're gonna evaluate the value Spain in the country. So what's gonna happen again, top down? This time none of those conditions gonna be fulfilled, right? So from the first one we're gonna jump to the second because it has false, as well from the second to the third it's false. That means we're gonna go and execute the else. Else can be executed if all conditions are not fulfilled. So in the output we will get the NA, not applicable. So it's very similar to the if else statements. Now we're gonna go and compare all those stuff side by side. So now we're gonna go and compare three functions: if statements, IIF, case when. I know that we didn't talk about the IIF, but now we're gonna check the syntax in order to understand the differences between it and the if statement. So let's start with the first one here. The syntax, we have multiple conditions. So we have two conditions. We have if sales higher than 1000, then high, else if sales is higher than 500, then medium, else low, end. So with that, we are evaluating multiple conditions in one statement. So now let's move to the next one. We have the IIF. IIF is very similar to the if else statements. We will get the same output, but we write it in different and easier syntax. So let's see the syntax. As you can see, it's very small. It starts with the IIF, then the condition itself, so the sales higher than 1000. Here we have two outputs, whether it's false or true. The first one is about the true, so if the condition is fulfilled, we will get high value, but if the condition is not fulfilled, we will get the low value. So here we're gonna write what can happen if it is false, and here we're gonna write what can happen if it is true. So if we compare it to the if else statements, it is easier to write and as well shorter. So here we don't have like keywords like else, or at the ends we don't have the keyword end, so it's really short and quick to create. But here of course we can evaluate only one condition. So now we can move to the case when. As we learned before, it's going to evaluate the values, the members of a dimension. So here we're going to evaluate the country, then we have multiple conditions. If none of them is fulfilled, we're going to go to the else statements, and then we have an end. So now let's learn the main differences between them. The first one is about whether it's going to support multiple conditions. As you can see in the if else statements, we can add many conditions as we want. So it supports multiple conditions. The IIF supports only one condition. The case when as well supports multiple conditions. Okay, so now let's move to the next one. We're going to talk about whether it's going to support multiple fields. The if else statements can support multiple fields, so we can have in the condition not only the sales but something else like the country as well. So the if else statements support multiple fields. The same for the IIF, it supports as well multiple fields, but in the case when it supports only one dimension. So here we cannot evaluate multiple dimensions in the same case when statements. So here only we are talking about the country. We cannot add any other fields inside these statements. So here we have a limitation in the case when statements compared to the other two. So now let's talk about supporting the data types. The if else statements and the IIF, both of them, they support any data type. That's why I said here it's gonna evaluate multiple fields. So here we could have a dimension, a measure, any data field that you have in your data source, it could be evaluated inside those conditions. But the case when here we have another limitation, we can evaluate only string values, only dimensions. So here we cannot go and evaluate, for example, the sales or profit or a quantity. So any measure, we cannot use it inside the case when statements. It should be exactly a string. We cannot even use, for example, a date, the order date. So here the field should be a string value. So now let's go and check the main advantage of each method. The first one is, as you can see, we don't have any limitation. The IIF here, the advantage is easy and quick to write. And in the case when here we have again the advantage of easy to write and to read. So if you look at the case when statements and to the if else statements, you can see the case when is like organized, it's easy to read, it has like a flow. It's compared to the if else. Here we have a lot of different keywords and Like, it's not that easy like the case when. So here my recommendation for you is, if you are evaluating only one condition with the output of 2 values, then always use IIF. It's very quick to create. But now if you have multiple conditions and you want to evaluate it, then think about the case when. Is it like data type string? Are you evaluating only one field? If that's the case, then use case when. It's easier to read and as well to write. But if you are talking about multiple fields and not only string values, then you have to go to the if else statements. Always start with the IIF, then the case when, and then if you don't have any other option, go to the if else statements. Alright, so that's all about those methods. We're gonna go now and practice in Tableau. Alright, so now let's go to the small data source. We're gonna go to our customers. Let's grab the first name to the view and as well the country informations. So now the task is to create country abbreviations, shortcuts from the original values that we have inside the country. In order to do that, we can use the if else statements, and we're gonna do that step by step. So let's go and create first a new calculated field. Let's call it country if. So now we're going to use the keyword if, and after that we have to specify our condition. So the first condition going to be if the country equals to Germany, then the abbreviation going to be DE. So let's create that. So if the field country equals to the value Germany, make sure to write it exactly like our data, capitalized, because Tableau here is case sensitive. So now what happens if the country equals to Germany? We would like to see in the output the word DE. So if it is true, we're gonna get DE. If it's not true, then let's try the first one, that we just exit. We don't have any else statement or any other condition. So that's it. So this is the simplest form of the if statements. Let's go and hit OK. So now as usual, we're gonna get a discrete dimension in the data source pane with the data type string, because the output is a string. We have the abbreviations. So let's drag and drop on our view to see the values. Alright, so now let's go and check the values for the first customer. You can see that the value is not equal to Germany. It is not fulfilling the requirement. We will get null. The same thing for John as well, USA, not fulfilling the requirements. So we will get null as well. For the next 2 customers, you see they fulfill the requirements and their condition. That's why we will get the value DE for both of them. And for the last customer, Peter, you can see the value is not fulfilling their condition. We're gonna get null. So as you can see, we are getting only one value DE. Otherwise, it's gonna be null. Alright guys, so now let's go to the next step, and I would like to get rid of those nulls. I want to see a real value in the visualizations. So if the condition is not fulfilled, I want to see the value not applicable in A. So now in order to do that, we have to use the else statements in our calculation. So now let's go to our field, and instead of changing the calculation inside this field, I would like to duplicate it and make a new one. So let's duplicate it and then edit the new one. I'm just gonna call it if else. And now we're gonna have the same condition again. If the country equals to Germany, we're gonna get DE. Otherwise, we will not skip. Otherwise, we can add the else statements. So it's gonna be always before the end. And after that, we don't add any condition. We just have to add the value. So the value, if the condition is not valid, gonna be not applicable. So that's it. That means if it's true, we're gonna get DE. If it's not, then we're gonna get the not applicable. Let's go and click OK. And we're gonna go and check the values as well in the view. Just make it a little bit bigger to see those informations. And now as you can see, instead of having nulls, we are having now a value, which is really better for the visualizations and as well for the user experience to have value instead of nulls. Nulls is always ugly in the views. And with that, we're going to control which value can be presented to the end users if the conditions are not fulfilled. So now, as I recommended before, if you have only one condition where the output is only 2 values, then the best way is to do IIF. So let's go and create it. We're going to go and create a new calculated field. We're going to call it country IIF. And let's see the syntax. So it starts with the keyword IIF. And here, as you can see, it needs 3 arguments. The test, it's going to be the condition. What can happen if the condition is fulfilled? So we have to specify it in the second argument. In the third one, what can happen if the condition is not fulfilled? So the condition is if country equals to Germany. So this is the condition. What can happen if this is true? Then we're going to have DE. Then the next step is to define what will happen if the condition is not fulfilled. So the country is not Germany. It's going to be NA. So as you can see, it's very quick and very fast to create such a condition and compared to the if, else, and so on. So this is the quickest way in order to create such a condition. So let's go and hit OK and check the results. So with that, again, we're going to get a new dimension. Let's drag and drop it over here in the view to check the results. Just going to make it a little bit big. So as you can see, we're going to get the exact result as the if else statements. So the first two countries are not fulfilling the condition, we're going to get NA. The next two customers, they are from Germany, we're going to get DE, and the last customer is not from Germany, that's we are going to get NA. So this is the magic of the IIF. Not a lot of people use it, actually. It's not that common to be used, but it is very nice way to quickly create conditions in Tableau. I totally recommend you to use it. Alright guys, so now we're gonna move to the one more step where we're gonna add another condition. So we don't have only one, we can have multiple conditions. That's why we cannot use the IIF. We have to go back to the if else statements. So let's see how we can create it. I'm gonna go and duplicate again one of those fields. So let's go and do that, and then let's go and edit it. I'm just gonna call it if else if statements. So we're gonna stay with the same informations, right? The first one we are checking the Germany, so this is the first condition, and else gonna be an A. So now we're gonna go and add a new line between the if and the else, and we're gonna add a new condition by adding the keyword else if. So it's like the if statements, we're gonna write our condition. So if the country this time equals to, let's say, France, then what's gonna happen? We can have the abbreviation FR. So that's it. With that, we have added our second condition, and as usual, we start the execution from top to bottom. So the first condition to be checked is if whether the country equals to Germany. If it is not correct, then it's gonna jump to the next condition. So let's go and hit OK to check the results. So let's go and grab it from the data pane and drop it on the view. And now we can see that there is one customer with the new data. So as you can see, George from France, we got the abbreviation of FR, and that's because the country equal to France, and with that we are fulfilling the second condition. The USA for John and Peter, they still don't fulfill any of those conditions. It always be executed from the else, and Maria and Martin gonna be executed from the first condition, where the answer gonna be DE. So that's it. Now we're gonna go and add the final step where we can add the third condition for the country USA, because we still are getting those not applicable for those two customers. I'm gonna go to the same field. This time I will not duplicate it. So let's go and edit it. And we just have to add one more condition, right? So I'm just gonna copy those stuff. And then as the next condition, it's gonna be as well, else if country equal to, this time USA. Then what's gonna happen if this condition fulfilled? We're gonna get the abbreviation US. So as you can see, it's very simple to add one more condition in the else if. Let's go and hit OK. So now we can see in the results, all those customers that come from USA, they have now the US abbreviation. And with that, we have covered everything with conditions, and none of those customers can be executed from the else. So we don't have the NA anywhere in the output, which is really nice. And now we can see in the view very nicely how we started with the simplest form of the if statement, and we end up with the complete form of the if statement. So now next we're going to solve the same task, but this time using the case when statements. Alright, so now let's go and create a new calculated fields. We're going to call it country case when. Then the syntax starts with the case, then we have to specify the field that we want to evaluate. It's going to be the country. So once we do that, we start defining now our condition. The first condition going to be the Germany value. So when the value equals to Germany, then what's going to happen? We're going to have the abbreviation DE. So that's it. The next condition going to be when country equals to France, then the abbreviation going to be FR. And we're going to go to the last condition. When the country equals to USA, then the value going to be US. So that's it. You see how quickly we defined three conditions using the case when. It is very logical and as well very easy to create, right? So now if none of those conditions are fulfilled, let's get the not applicable and we have to end it. So that's it. As you can see, the calculation is valid and it's really easy to read as well, right? So it is everything like structured. I liked a lot using case when statements in compared to the if else. So that's it. Let's go now and hit OK to check the results. And now we got a new dimension as usual from the calculated field. Let's put it in the view to check the results. So as you can see, we're going to get the same results, but in this situation for this task, I'm going to recommend you to use the case when, since as you can see, it's very easy to write and as well to adjust later or to add more conditions if it's needed. So with that, we have learned how to use all those logical operations in order to create new logical conditions. Alright everyone, so now I'm going to show you a very common use case that you might find it in many projects where you're going to go and create the colors of the KPIs using the logical conditions. So let's go to the big data source and we need the subcategory from the products as usual to the rows, and then we need the sales from the orders. So let's put it on the columns and then we're going to sort it We're gonna add the labels, and now we need the colors for this KPI. So let's go and create our new calculated fields. We're gonna call it KPI colors, and the logic can be the following. If the sum of sales are higher than 200Ks, I would like to see the green color. Anything between 200Ks and 100K is gonna be the orange color, and anything below the 100K, it's gonna be red. So now we have to decide on the method that we want to use in our calculation. As I recommend, you always start with the IIF. So now in the logic, we have multiple conditions. We cannot use it. So IIF is only suitable if we have only one condition. So IIF is away. The next one, we're gonna talk about the case when. But since the conditions are based on the sum of sales, it is integer, we cannot use the case when because case when can accept only string values. So this is as well away. We are left only with the if else statements. That's why in this calculation, we're gonna build it based on the if else. So let's go and do that. We're gonna start with the context over here with the if, and then we have to specify our first condition. Anything higher than 200Ks, it should be green. So now we are talking about the field sales, but in the sum, because in the visualizations, we have the sum of sales. So if the sum of sales is higher than 200Ks, then what's gonna happen? We're gonna have the color green. So that's it for the first condition. Now we have to specify the condition for the orange. So anything between 200K and 100K, it should be orange. So let's go and specify that. So else if, again, we're gonna have the same field, sum of sales higher than 100K, then it's gonna be orange. So now you might say, you know what, in the condition that you just say, it has like two boundaries, right? Higher than 1000 and lower than 2000. Well, the first boundary, we have it already with the first condition checked. So if it is higher than 200Ks, it's gonna get green, and this is gonna be skipped. So anything gonna be checked in this case is gonna be lower than 200K. That's why I specified here only the lower boundary. So that's it for the orange. The last one is gonna be if the sum of sales is lower than 100K, what's gonna happen? We're gonna get red. So let's go and specify that. We're gonna have another else if sum of sales and lower or equal than 100K, then it's gonna be red. So with that, we have covered the third condition, the third color, and we covered everything. We covered all possible values that could happen. That's why it doesn't make any sense to make an else statement. We just can go and end it. So now let's check everything is fine. Now we got an error because I think I missed here to close it. So now let's check it again. The calculation is valid. So that's it. We have three conditions to three colors. Let's go and hit OK. Alright, so now we have our dimension over here. We're gonna use it for the coloring, right? So let's drag and drop it on the colors over here. And now as you can see, our colors are splitting our view. Tableau got it almost correct. So we have here orange, red, but this one is not blue. So let's go and change it. We're gonna go to the colors, then edit colors. And now instead of green as blue, we're gonna have it as a real green. So let's go and hit OK. So with that, we got the colors of our KPI. So as you can see, all those subcategories with the sales are higher than 200K. They are all green as supposed to be. And now anything between 200K and 100K, as you can see, all of them are orange, and anything below is red. So as we can see, we can do a lot using those logical conditions. We can use it in order to create the coloring in Tableau. We can use it to create new informations like in the country abbreviations. They are very necessary to understand. Alright, so far we have learned how to create conditional logics in Tableau and how we evaluate it in order to manipulate our data based on the decisions. Next, we're gonna start talking about the logical operators and or not. Okay, so now we're gonna learn how to combine, how to evaluate multiple conditions in Tableau using the logical operators and or. Then we're gonna learn about the not operator. So let's go and understand the concept, then we're gonna practice. Let's go. Okay, so now let's start with the and or operator. Let's have the following scenario. Let's say that we have one condition where we are checking whether the sales is higher than 100 and a second condition where we are checking whether the country is Germany. So now if you want to go and evaluate both of them, you want to combine those two conditions together so that they work together, we can use the and or operator in between. So here we can use those two operators to combine the condition A with the condition B, and the output can be as well as usual a boolean true and false. So our two operators and or, they are logical operators that are used to combine multiple conditions. So now let's say that we're going to use them in if-else statements. Let's see how the syntax is going to look like. Let's start with the AND operator. So as you can see, we have here the if statements, then we have our two conditions, and in between them we have the AND operator. So the condition going to combine both of them in one statement. So if the sales is higher than 1000 and the country equal to Germany, then we're going to get the value high if it is true. Otherwise, it's going to end and we will get null. The same thing for the OR operator. We are saying here, if the sales is higher than 1000 or the country equal to Germany, then we're going to get the value high. So as you can see, it's really simple. Let's check an example in order to understand what are the differences between and or. So now we have in our table 4 customers with their sales informations and the countries. So the first condition gonna check whether the sales is higher than 1k. So now let's check the first customers. We're gonna get true because the sales is higher than 1000, and the last two gonna be false because it is below 1000. So this is the information from the first condition. Then the second condition that we have, we're gonna check whether the country equal to Germany. So the first customer is from Germany, that's why it's true. The second one is not, we have it false. Then the next one is Germany, true, and the last one is false. So now as you can see, we are evaluating the table first in order to get the result for each single condition. But now what we can do is we can go and combine those two conditions to generate new results. So now if you go and use the AND operator, it's gonna return true only if both conditions are true and false otherwise. So now let's go and combine those two conditions together using the AND operator. Let's check the first customer. We have the condition A is true, condition B is true as well. So we are fulfilling the requirement to get it true. So for the first customer, we're gonna get the output true. For the next customer, Maria, we have in the condition A, true, but in the condition B, false. So it does not fulfill the requirement. Both of them should be true to get it true. That's why it's gonna be false. For the next one, Martin, gonna be the same. So the condition A is false. The condition B is true. Both of them should be true. That's why we're gonna get false. The last one anyway, both of them are false, so we're gonna get false. So as you can see, the AND operator is very restrictive. Both of the conditions should be true in order to get true. Otherwise, immediately you will get false. So this is how the AND operator works. Let's go to the next one. We have the OR operator. OR operator can return true if at least one condition is true. Otherwise, it's going to be false. So that means we need at least one true to get true in the output. So let's go and check the example again. For the first customer, we are fulfilling the requirement. We have more than one, so both of them are true. That's why in the output, we will get true. The next one, we have true at the condition A, false at condition B. At least we have one, so we are fulfilling the requirements. It's going to be true as well. The third one is the same, so we have at least one true in the condition B. That's why for Martin, we're going to get a true. But for the last customer, George, both of them are false. So we need at least one true to get true. That's why the output going to be false. So as you can see, the OR operator is less restrictive than the AND. We need at least one true to get true at the output. So this is how the AND and OR operator works in Tableau in order to combine multiple conditions. One more thing to notice here as well is that if you are using AND and OR, we are evaluating the end result of the condition. So we are not evaluating the table itself, we are evaluating those results that we got from the conditions. Okay, so now we're going to talk about the third operator, the NOT operator. So let's take an example. We're going to have the following table and we have our condition where the sales is higher than 1000. So we will not use the NOT operator to combine two conditions together like with the AND OR operator, but this time we're going to reverse the results of the condition. So the NOT operator is a reverse logical operator. It's going to return true if the result of the condition is false, and it's gonna return false if the condition is true. So if you tell it to go right, it's gonna go left. If you tell it to go left, it's gonna go right. So it's gonna do exactly the opposite. So let's see what's gonna happen if we say not this condition. So if you use the not operator for the first customer, you will get false because the value is true. The same for the second customer, you will get false. But for the next two customers, you will get true because the output of this condition is false. So as you can see at the result, we're gonna flip the truth. We're gonna get exactly the opposite if you use not. So it's gonna look like this in the calculation in Tableau. So here again we have our if statement, our condition, but just before the condition we're gonna go and put not, and with that you are reversing everything. So now what we are saying here in this condition, if the sales is not higher than the 1000, then we're gonna get the value low. So that means anything equal to 1000 or smaller than 1000, it's gonna be low. So we are reversing the results. So that's it. This is how the NOT operator works. Now let's go back to Tableau and practice those three operators. Alright, so now we're gonna go to our big data source. Let's grab the informations of the customers to the view. So we're gonna get the customer ID, the first name, country, and the scores as well. But I would like to show the discrete values of the scores. So let's switch it to discrete. And then we need a measure. Let's go to the orders and get the sales. So put it in the columns, and as you can see now we have for each customer the total sales that they ordered. So now the task is to not show all the sales of all customers. We want to focus on specific group of customers. So now we want to show the sales for only customers that come from Germany and their score is higher than 50. So with that we have two conditions, and we can go and use the AND or operator in order to combine them. So as usual, we're gonna go and create our new calculated field, and we're gonna call it sales AND. So we're gonna start with the if statement. Now we need to write our conditions. So the first condition, the country should be equal to Germany. So the country field, we have it over here, must be equal to Germany. And now since we are saying AND in the tasks, it's gonna be here as well, and in order to connect the second condition. So the second condition, the score should be higher than 50. So the field score should be higher than 50. So now we have our two conditions. Both of them are connected with the AND operator. So now if both of them are true, what can happen? We're gonna show the value sales. So next we're gonna say then sales, and otherwise it's gonna be null. So that's it. We're going to go and end the statements. So with that, we can see that the calculation is valid. Everything is fine. So let's go and try what's going to happen. Let's go and click OK. Now we have our new field in the data pane on the left side. It's going to be continuous measure because the output going to be sales. So now we're going to go and check the values. But first, I would like to get rid of those bar diagrams. I'm just going to move the sales to the details and then move it again to the view over here at the APC. So now we have those values. Let's get our new sales with the AND operator and put it as well on the view. Just let's make it a little bit bigger to see the headers. Alright, so now let's go and check some customers. Let's take the customer number 2. You can see the country equal to Germany. So we have the first true and the score as well higher than the 50. So we have another true. With that, we're gonna get the output to true. That's why we are seeing the value of the sales at the output. So let's move to the next one. We have the customer number 3. You can see the country is not Germany. So we have here France. So the first condition going to be false, and immediately the output going to be false because both of them should be true. But we can check the second value. You can see the score is as well not higher than 50. So both of them fails and the output going to be fail as well. So that's why we are getting empty. We are not getting the sales. Alright, so now let's move to another customer, number 23. You can see the customers comes from Germany. So the first condition is fulfilled. So we have our first true, but the score is not higher than 50. So the second condition failed. That's why we didn't get any results. So as you can see, the AND operator is very restrictive. Everything should be true in order to get the results. So that's it. This is how the AND operator works. Let's move to the next example where we want to show the sales only for the customers that they come from Germany or the score is higher than 50. So the logic is very simple, right? But here we have to change the operator on how we are combining those two conditions. So we're going to have the same thing. That's why I'm going to go to the sales and let's duplicate it. And then we go and edit it. So we're going to change the name to or. And we have the same conditions if the country equals to Germany, but this time or the score is higher than 50. So that's why I'm going to go over here and let's change it to or operator. So now I would like to mention something that those logical functions are very close to the English language. So if you just read this code, it's like you are saying a sentence in English. So what we are doing here is if the country is equal to Germany or the score is higher than 50, then show the sales. That's it. So you see, it's like translating the English sentence to a code, and it's really easy to write and to read as well. So it's really logical. So now let's back to our calculation. You can see it is valid. Let's go and hit OK. And immediately we can see in the view that with the OR operator, we are getting more values than the AND because the AND is very restrictive. So now let's go and check some customers. You can see the first one, we have the country not equal to Germany, so come from France. The first condition failed. So let's have hope for the next one, but the score is higher than 50. So that means this customer gonna fulfill the requirement. It's enough to have only one true. So that's why we have the sales in the output. The next customer fulfilled both of the conditions, come from Germany, higher than 50. That's why we have the sales, like the AND operator. But the third customer, as you can see, the first condition failed because France, and the second as well failed because the score is not higher than 50. That's why both of them are failed and we don't have any results. We have to have at least one true to get something at the output. So that's it. This is how the OR operator works. Alright, so now we have the following task for you is to show the sales for only customers who either come from Germany or France. You can pause the video now in order to complete the task, and once you are done, you can resume it. Okay, so let's see how we can do that. We're gonna go and create a new calculated field. We're gonna call it sales country. And we're gonna start with the if statements. Then we have the two conditions. The customer should be either from Germany or France. So the first one gonna be the country equal to Germany, and the operator gonna be or. So the customer could be either from Germany or France. So country equal to France. So what can happen if one of those conditions are fulfilled? We're gonna have the sales, then sales, and that's it. Let's end it. So as you can see, very simple. Let's go and hit OK. So as usual, we're gonna go and check the values. So let's drag and drop it over here in the view. We have it here in the middle. Let's just make it a little bit bigger and see the customers. So now we are checking only one field, but in two conditions. So either the country France or Germany. So the first customer we can see come from France. We're gonna get the value. The second one as well, we're gonna get the sales value France. USA, we will not get any value because it's not part of the condition. So as you can see now, we are getting the sales of all customers that come either from France or Germany. Okay, so now I'm going to show you quickly something. Let's go back to our calculated field, sales country, and go and edit it. So now instead of having or, we're going to use the operator and. So now what we are saying is the customer should come from Germany and at the same time from France. So it sounds weird, right? So let's go and try it. Let's hit OK and check the results. You can see that the sales country is completely empty. So we don't see any values because in our situation, the customer should only come from only one country. So we cannot have this condition. So logically, from the data perspective, this is not possible. Alright guys, so with that we have learned the AND OR operator. Let's move next to the NOT operator. Okay, so now we have the following task. Show the sales of all customers who don't come from Germany. So if the customer come from any other countries, we're gonna see the sales in the view, but if the customer from Germany, it should be null. Alright, so now let's go and create a new calculated field. We're gonna call it sales not Germany. And we're gonna have as well the if statements. So now we have two ways to do it. So the first option and the long one, where we're gonna go and create a condition for each value inside the country beside Germany. So we're gonna do something like this. So country equal to USA, and then we're gonna say or country equals, for example, Italy, and then for the next one, or country equal France. So as you can see, I'm creating a condition for each value from the dimension country. So of course, if you have a long list of countries, you're gonna end up making a lot of conditions. And as well, what can happen if a new country enters inside your data source, what's gonna happen, you're gonna always go to the calculation and add it as a condition. So in this option, we are including all the values that we want to see in the view, but there is a better way to do that where we're gonna exclude only Germany. So let's go and remove everything from here. So we're gonna say if the country equal to Germany, and this time before the condition we're gonna add the operator not. So here we're gonna go and reverse everything. So if the customers don't come from Germany, what gonna happen? We're gonna show the sales, then sales, and that's it. So as you can see, it's very short and simple. We are just excluding one values. We don't have to add all the values. We don't have to be worried about if there is like a new country value inside the data source. Anything not Germany, we're going to show the sales. So let's go and check the values. I'm going to go and hit OK. So now as usual, we're going to get a new calculated field in our data source. Let's drag and drop it to the view to check the values. Just make the header a little bit bigger to read it. Then scroll up and the first customers come from France. We're going to get the sale informations. The next one from Germany, we have null. Here we have as well the customer 5 from Germany, 6 as well from Germany. We don't have any sales informations. So with this, we can see that all the customers that don't come from Germany have the sales in this field. So as well, we can check that by sorting the countries. Let's sort it like this. And all those values from France, we're gonna get always sales informations. And if we go to Germany, you see all the customers from Germany don't have any sales informations in this field. So there you see, we're gonna get again the values. So as you can see, it's really easy to use and really useful to make filters and so on, and as well to focus on specific group of customers in our views. So that's it about the 3 operators. They are really nice to use. Alright everyone, so that's all for the logical operators, and with that we have covered all 8 logical functions in Tableau. They are really important functions since it's gonna help us to make data-driven decisions in the analysis. And with that, we have covered the last group of functions under the category row-level calculations. We learned around 40 Tableau functions. And next, we're gonna learn about the aggregate calculations in Tableau. Alright, so now we're going to talk about the second type of calculations that we have in Tableau, the aggregate calculations, and I split the functions into 2 groups. The first group going to aggregate the measures in our data source, so we have the sum, average, count, and so on. And the second group where we can aggregate the dimensions of our data source, and here we have only one function, we have the attribute. So now we're going to focus on the first group, how to aggregate the measures in Tableau. Alright, so the first question is, what are aggregate calculations in Tableau? If you use those calculations, you're gonna aggregate the rows of the data source and put the result at the visualizations level of the details. So that means the dimension that you are using in the view gonna control the granularity of the measure. Let's have a quick example in order to understand it. So let's say that we have the orders table inside our data source, and we would like to find the total sales by the products. And in this example, the sales is a measure and the product is the dimension. So in order to find the total sales, we're going to use the function sum in Tableau. So it's going to look like this. We're going to use the sum of sales, and in the view, we're going to have one dimension, the product. It is the one going to control the level of details in the view. And then we have the result of the function sum. So we're going to put here the results of the aggregations. So now with this, Tableau going to go and group up the rows of the orders by the products. So as you can see, the first group is based on the product number 1. Then we have the second group for the product number 2, 3, and 4. So as you can see, the orders now is divided into groups. And at the visualization levels, we're going to have exactly only one row for each group. So that means for the product 1, we're going to have only one row. And then Tableau going to go and summarize all the sales inside this group. So at the end, in the result, we're going to have the value of 40. So as you can see, the aggregate calculations is grouping up the rows from the data source and present it as one row at the output in the visualizations. Then Tableau gonna move to the next group. For the P2, we're gonna have only one row, and the summarizations of the sales gonna be 50. And the same thing gonna happen for the product 3. We're gonna have here 2 rows, and the summarizations of that's gonna be 45. And as well for the P4, we have as well one row in the visualizations with only 15 as the total sales. So as you can see, the aggregate calculation is going to go and group up the rows of the data source and present it as one value in the visualizations, and the level of detail is going to depend on the dimension that is used in the view. That's why we say that the aggregate calculations going to bring the data at the visualization level of details. And it's not like the functions in the row level calculations where we have computed each value on the same row. So we didn't group anything. The number of rows going to stay exactly like before. So this is how the aggregate calculations works, and we don't have only one function, we have here multiple functions. So the first one, we have the sum that we just learned. It can return the total sum of all values within a field. And then we have another one, the average. It's going to return the average of all values. Then we have the count. It's going to count the number of values within a field. Then we have another very similar function called countD. This time we're going to count the number of unique rows within a field. Then we have the max and min. It's going to return the maximum value or the minimum value within a field. And now if you check the syntax of those aggregate functions, it's going to be the easiest if you compare it to any other functions. They all follow the same pattern. So they always start with the name of the functions, for example, the sum, average, count, and so on. And they all accept only one field. So as you can see, we have the sum of sales, average of sales, and so on. So we have only one argument, and it's very simple. So now let's go in Tableau and start practicing those aggregate functions. Okay, so back to our small data source, let's go to the product, and as usual, we're gonna get the category and as well the product name. So now those two dimensions gonna define the level of details, and the product name gonna be the one that is controlling. So here we have the 5 products inside our data source. And now in order to create aggregated calculations in Tableau, there are 2 ways. Either you're gonna do it locally directly only for this view, or globally by creating a new calculated field, and it's gonna be available for all other worksheets. So now let's go and check the first method, where we're gonna go and create a quick aggregated calculation. So we're gonna go to the orders and we're gonna take the sales. So just drag and drop it here on the view. And now, as you might already notice, that Tableau always try to aggregate the data at the visualizations, and for that Tableau gonna use the aggregated functions. So as you can see, we have the sales, but before it we have the sum of sales. So that means Tableau is using the function sum in order to aggregate the data in the view, and this is the default method from Tableau to aggregate the data. So that means in Tableau, the default type of calculations that can be used on the measure is the aggregate calculations, and the default function that's going to be always be used is the sum. And now in order to change the function that is used in the aggregations, we can go to the measure over here, right click on it, and here we see that our field is a measure and using the sum function. In order to change that, let's go to the measure, and we can find here a list of all different aggregate functions that we have in Tableau. So we have the sum, the average, the count distinct, minimum, maximum, and so on. So now, for example, we can go over here and change it to the average. So now instead of sum of sales, we have average of sales, and at the output we're gonna get the averages. So as you can see, it's very simple. With just one click, we change the aggregations function, and as well, it doesn't need a lot of configurations like we're gonna see later in the table calculations, for example, or the LOD expressions. So this one is really easy. If you want to change the function, just go to the measure, right click on it, and then here you have a list of all functions that you can configure. And of course, anything that I'm choosing now from those functions will not affect any other sheets and will not affect our data source. So here we still have the sales. We don't have here any field called the average sales. So it's going to be only locally available for this visualization. And that brings us to the second method, where we can create an aggregated function that is globally available for all other worksheets or workbook connected to the data source. Alright, so now let's say that I would like to have an extra field inside my data source to find the total of sales. In order to do that, we're going to go and create a new calculated field. It's really simple. We're going to call it total sales. And then in order to see the aggregate functions in Tableau, we can check the documentations over here. So let's go to all, and then let's choose aggregate. And with that, you can find all the aggregate functions in Tableau. Inside it, you can find as well the LOD expressions. So we have here the fix, include, and so on. So in order to find the total sales, we're going to have the function sum. And as you can see, it needs one expression. It's going to be the sales. So it's going to be only one field. So we're going to have the sales, and that's it. So as you can see, the calculation is valid, and let's go and hit OK. And with that, we got a new continuous measure inside our data source. But here the difference between aggregate calculations and the row level calculations is that those calculations gonna happen on the fly, where the row level calculations gonna store the data inside the data source. So that means if you go and check the data source data, or if you view the data from here, you can see that we don't have any information about the total sales. So now if you browse the data, we don't have any extra field called total sales. So because those informations will not be pre-calculated from Tableau and stored inside the data source, it can happen on the fly as you bring the field to the visualization. So that means Tableau will not go immediately and execute the aggregate calculations as you are creating them and then put the result in the data source. Tableau will do it on the fly, and that's because Tableau doesn't know the level of details that you need at the visualizations. As you know, the data source has the row level of details. So that's why only one type of calculations, the row level calculations, gonna be pre-executed and stored inside the data source, and the rest gonna stay on the fly. So that means our new calculated field using the aggregate functions will not store inside the data source any data. The data gonna be calculated once you drag and drop it inside the view. So it's gonna stay empty as long as you don't use it. So let's go and close this over here, and let's drag and drop it to the view to check the results. And now in this view, we got the total sales by the products, because the product name gonna control the level of details. Let's say that you would like to have the total sales by the category. In this view, you have to remove the product name. So in order to do that, we're gonna go and remove the product name from the view. And with that, we got the total sales for each category. So that means the aggregate calculations or the granularity of the measure is going to depend on the level of details of the visualizations. The dimension going to control everything, going to control the level of details that we see in the view. So now let's go and understand how Tableau brought those numbers to the view. Okay, so in the data source, we have 15 orders, and in the visualizations, we said, okay, we would like to have the category. So Tableau going to go and get the category to the visualizations, and inside there are like two values. So we're going to get the accessories and the monitor. So we're going to have with that only two rows. Then we're going to have the sales, the total sales. So Tableau going to go and aggregate the sales for each category. So as you can see, Tableau going to go and split the orders into two groups, the one with the category, accessories, and the other one with the monitor. Now, in order to find the total sales of the accessories, Tableau going to go simply and go aggregate all those values of the sales and put the result at the output. So the first one going to have like around 2,377. And for the next group, Tableau going to do the same. So we're going to go for all those orders underneath the category monitor and go and aggregate all those values. So with that, we're going to get around 4,129. So as you can see, Tableau going to go and split the rows by the dimension that is used in the visualizations. And in this example, it's going to be by the category. So it's going to split it into two groups and then going to go and apply the aggregate functions. Okay, so let's move to the next one. We would like to find the average sales for each category. In order to do that, we're going to go and create a new calculated field, and we're going to call it average sales. And the function is very simple. So it is the AVG, the average, and then we're going to have our field sales, and that's it. It's pretty simple. So let's go and hit OK. And as usual, we're going to get a new empty field inside the data source. But once we drag and drop it on the view, the calculation is going to happen. So let's do that. So with that, we can find the average sales for each category. And how Tableau did the calculations is very simple. Tableau going to split again the rows inside the orders into two groups. The first group for the accessories. So it's going to go and add up all those values inside the sales. And then it's going to divide it by the total number of orders inside this category. So here we have around 8 orders. So their final value going to be around 297. The same thing going to happen for the second group. So Tableau going to go and add up all those values, then divide it by 7 because we have only 7 orders for the monitor, and we will get 590 as a result. So here we can see again that the dimension category is deciding how the calculation going to happen and as well how the data going to be split up. So that's all for the average function. Let's move to the next one. We have the count. Let's say that we would like to find the number of orders for each category. In order to do that, we can go and create again new calculated field, and we're going to call it number of orders. And the function is really simple. So we're going to use the counts, and inside it we need only one field. This time we're going to go and count the order IDs. So in order to do that, we can go and use the order ID, and that's it. So we are counting how many orders IDs we have inside our data source. The calculation is valid. Let's go and hit OK. As usual, we're going to get a continuous measure in our data source. Let's go and drop it to the view and check the results. We can see that in the accessories, we got 8 orders, and on the monitor, we got 7 orders. So now let's see how Tableau is doing that. It's very simple. Again, our data is splitted into 2 groups, and Tableau going to start simply counting the rows. So how many rows do we have inside the accessories? It's going to be 8 rows. So we have here 8 orders, and if you count the rows of the monitor, you will get as well 7 orders. So with the count function, we are just simply counting the rows. So that means in the accessories we got 8 rows, and on the monitor we got 7 orders. There is one more special thing about the count. Let's say that inside our data we got nulls. Let's say that we don't have here any order ID. It's empty, it's null. So what's gonna happen here? Tableau will not count it. So in this example, Tableau gonna go and count only 6. So here instead of 7, we're gonna get 6. And this as well gonna affect the previous function, the average. As we learned before, it's gonna go and add up all those values, and then it's gonna divide it by the number of orders. So let's say that we have here a null. This time, Tableau will not divide it by 7, Tableau gonna go and divide it by 6. And here again, a reminder that we have to handle the nulls inside our data, as we learned before, using the ZN or isNull, ifNull, and so on. So if we divide it on 6, it's gonna be different than dividing it by 7, which is more correct. So here we have 7 orders and not 6 orders. So that means pay attention if you feel that you are doing the aggregates on top of it, whether it has nulls or not, because having a null here, we're gonna get inaccurate results. we don't have 6 orders, we have 7 orders inside the monitor. Alright, so that's all for this function, the count. Alright, so now we're going to move to a very similar function in Tableau called the countD. It's going to return the number of unique or distinct values within a field. It sounds very similar to the counts, but here we have a difference between them where we are counting only the distinct values. Let's have an example in order to understand that difference. We would like now to show the number of products for each category. Let's go and create a new calculated field, and let's call it number of products. And this time I'm going to start first with the function count to show you the differences between them. And we're going to use the field product ID. Let's go and select that and then hit OK. Again, we got a new calculated field. Let's show it at the results. And we can see that the results is very similar to the number of orders. So here again, we have 8 products for the accessories and 7 products for the monitor. So now what happened here? Well, if you check the data inside the order, we got only 2 products with the accessories and as well only 2 products for the monitor. So why we got 8 and 7? And that's because Tableau gonna go and count the number of rows, whether it's like duplicates or not, it doesn't matter. So Tableau gonna go and count. Okay, here we have 8 rows, so that means we have 8 products. So that's why we cannot use the count function for this task. We have to use another thing where we're gonna use the countD. So let's go and change it. I'm gonna go to the calculated fields, edit, and just add a D after the count to use the next function. So we have count product ID. Let's go and hit OK. And as you can see in the result now, we got 2 for the accessories and 2 for the monitor. So let's see how Tableau gonna work here. Tableau gonna count the distinct or unique values within a field. So this time Tableau gonna pay attention to the content of the field. So it's gonna start counting. Okay, here we have the USB mouse, so this is 1. Then the next one we have the same information, so Tableau will not count it at all. The same for the third. Then for the 4th order we have a new product, so here we have a new value, the Logitech keyboard, so here we have 2. Then move on to the same stuff, so here we have the same values. Tableau will not count them. So at the end Tableau did count here 2 unique values. So here we have 2 products for the accessories. That's why Tableau gonna go on the output and put 2 for the next category. So we start with the same. So we have the LG full HD monitor. This is 1 product. The second one is the same value, so we'll not count it. Then move to the third one. As you can see, it's a new product, a new value, so it's gonna count 2, and the rest will not count anything because it as well duplicates. So Tableau gonna go and count the number of unique values within a field. So that's why we can have as well here a 2, which is more accurate. We got only 2 products for the accessories and only 2 products for the monitor. So this is the difference between count and countD. Count will just blindly go and count how many rows do we have inside each category, but countD gonna go and check the content and it's gonna count only the unique and the distinct values. Alright, so now we're going to move to the last 2. We have the max and min. They are very simple functions in Tableau. The max going to find the highest value within a field, and the min going to find the lowest value within a field. Let's go and check how it's going to work. So let's say that we would like to show the highest sales for each category. In order to do that, we're going to go and create a new calculated field. Let's call it highest sales, and then we're going to use the max function. And we have the sales. It's very simple. It always needs 1 field. So that's it. Let's hit OK. And let's check the results. Let's put it on the view. So here we can see the highest sales inside the accessories is the 525. And the highest sales for the monitor is the 1691. So let's see how this works. As usual, our data is split into 2 groups. We start with the first group. So Tableau gonna go and check all those values. What is the highest values? Inside those sales, it's going to be the 525. So Tableau going to present it as the result. Then we're going to move to the second group. So Tableau going to take all those values and compare it to each other's in order to find the highest value. And it's going to be this order number 2 as a highest sales inside our data for the category monitor. So that's it. This is how the max function work in Tableau. Let's go to the next one to find the lowest sales for each category. So we're going to do the same stuff. We're going to have new calculated field, lowest sales, and this time we can use the function min and then our field sales. So that's it. Click OK, and let's present it as the result as well to compare it. So here we can find the lowest sales in the accessories is 56 and the lowest as well for the monitor is 40. So the same thing, Tableau gonna go and check all those values for the first group. What is the lowest sales? As you can see, it's gonna be this order number 10. going to be the lowest value, and then Tableau going to go and check those group of values. In order to find the lowest value, it's going to be this one, the 39. Tableau is just rounding the numbers, that's why we have here 40, but in reality it is 39.97. So that's it. This is how the max and min works in Tableau. As you can see, the aggregate functions in Tableau are very simple. Those functions, like, I think this is my easiest tutorial that I made in the Tableau series. Alright guys, so that's all for these 6 functions in order to aggregate the measures of our data source. Next, we're going to talk about how to aggregate the dimensions using the very confusing function, the attribute. Alright, so now we're going to talk about another aggregate function in Tableau, but this time, this function is going to be very special and it is very confusing. A lot of people get confused about the attribute function in Tableau. So first, as usual, we're going to understand the concept behind it, and then we're going to practice in Tableau. Previously, we have learned that the aggregate function is going to go and aggregate the numbers, the measures inside our data source. This makes sense, right? To have the total sales in the view. But now how about to aggregate the values of the dimensions? For example, the customers or the products. How to aggregate those values? We cannot go and use the sum function. In order to aggregate the dimensions, we can go and use the attribute function. So the attribute function in Tableau gonna go and aggregate the values of the dimensions of the data source and present the result in the view. But this time I would like to go and aggregate the values of the customers by the products. So in order to do that, we can use the function attribute for the customers, and in the view we can have 2 values. So first we have the dimension product. This one gonna define the level of details of this view, and here we have another field where we're gonna have the result of aggregating the customers, so the attribute of the customer. Here we have 2 options. The first one, if all values are same, then it's gonna return a single value, the same value. Or if we have multiple values, then it's gonna return asterisk. This might sound very confusing or complex, but don't worry about it. Let's just follow the example. So again here, since we are grouping up the data by the products, Tableau gonna go and group up the orders by the products. So the first group for the product number 1, the second group for 2, and so on. And in the visualizations, we're gonna have only 1 row for each group, like any other aggregate functions. So now for the first group, we're gonna have 1 row, the pay 1, and Tableau gonna go and check the values inside the customers for this group. So as you can see, we have the same informations in those 3 rows. So we have John, John, John. So we have the same value. So we are at the first options. If all values are the same, then it gonna returns a single value. That's why Tableau gonna return in the output John. So with that, Tableau did implement the first option. Let's go to the next group, so the pay 2. As you can see in the customers and the pay 2, we have here different values. So the first one is John, the second one is Maria, Maria. So we don't have same values, right? We have different values. That's why Tableau gonna go and execute the second option, because we have multiple values and Tableau gonna return asterisk. So that's why we have here an asterisk at the results. So this is how the attribute function works in Tableau. Let's move on to the next products. Let's see that we have the P3, and as you can see, we have here again 2 different values, John and Maria. They are not the same. That's why the second option gonna be activated and Tableau gonna have the asterisk at the results. For the product 4, let's check. We have Maria and Maria. So we have the same value. That's why Tableau gonna go and execute the first option where all the values are same, and then we're gonna get the same value in the output. That's why we have Maria. So that's it for the attribute function. It's really simple, right? Once you have an example, then everything gonna be clear. So again, if the values are the same, like here, John, then you're gonna get the same value. And if the values are different, so you have multiple values, then Tableau gonna have the asterisk. And now you might ask what this asterisk means in the view. Well, Tableau use it as a highlight or warning for you to tell you there are more details in this field inside the customers. And the asterisk is gonna help you as well to understand the relationship between dimensions, between, for example, the customers and the products. As you can see, for the product 2, we have multiple values. So it is like 1-to-n relationship, but for the product 1 we have 1-to-1 relationship, so we have only 1 customer for only 1 product, and with that you can understand the relationship between dimensions. Alright, so with that we have understood that in Tableau we can of course aggregate the measures like in the sum function, but as well we can go and aggregate the dimensions inside the data source using the attribute function in Tableau. So this is the main task that we usually use the attribute function to aggregate the dimensions. So now let's go back to Tableau in order to practice this function. Alright, so now I'm going to show you a very quick example on how to create the attributes in Tableau. So let's stick with the small data source. Let's go this time to the customers. We're going to take the countries and the cities as well to the view. And now I would like this example to go and aggregate the dimension city inside this view. So in order to do that, we can use the function attribute. There is two ways to do it, either globally and locally as usual, locally only for this view, globally for all other worksheets. So let's see the quick one, the local one. In order to do that, we go to the city over here, right click on it, and then you can find this option between the dimensions and measures. This time we have the attributes. Again, this is not the third option of the metadata that we learned before, dimensions and measures. This is simply an aggregate function that Tableau just put it between those two options. So it is not the third option, it is an aggregate function. So let's go and click on that. So now we can see from the name of the field, we have the function attribute applied on the field city. And the level of details in our visualizations is not anymore the city like before, it is now the country. So the city gonna have an aggregated value. So for France, we have Paris. For Germany and USA, we have the asterisk. So let's see quickly how Tableau did that. Okay, here is very special about the attribute function in Tableau. It's not like all other aggregate functions where we start from the data source. Here we start from the visualizations. So it depends on the visualization level of details that we have inside the view, it's gonna do the calculation. So here we have the visualizations, the country and the city. So it's gonna focus only on those two dimensions. And at the start we have France, Paris, and we have two values for Germany and two values for USA. Since the country is the only dimension that we have in the view and the city gonna be an aggregation, the level of detail is gonna be the country. That means we're gonna have only 3 rows, only 3 values. So Tableau gonna show us, as we can see here on the left side, that we have France, Germany and USA. So now, as we learned, Tableau gonna go and check the values. If all values are the same, we're gonna get the same value. So for France, we have only one value, so it's gonna be the same value. Tableau gonna go and put it at the output. Then the next one, Germany, we have this group of rows. So we have 2 rows, Berlin and Stuttgart. We have 2 different values. That's why Tableau gonna go and put the asterisk at the output. The same for the USA. As you can see, we have here 2 different values. So we have multiple values. And for that, Tableau gonna show as well the asterisk at the outputs. And that's why we have here only Paris for France and 2 asterisks for the other 2 countries. So as you can see, this is very simple. Let's go to another example to understand the use case of the attributes. Alright everyone, so now you might ask, okay, nice, we can now aggregate the dimensions, but where do I use it in my dashboards? So what are the real use case for the attribute functions in Tableau? Well, usually I tend to use the attribute functions in 2 use cases. The first one inside the tooltip, where I want to show for the users more details about the aggregations. Let me show you how I usually do it. Let's go to the big data source, and then we're gonna go to the customers. Let's take, for example, the country, the city, all informations about the location, and as well the postal code. Then as usual, we would like to show the sales informations. So let's go to the orders and take the sales to the columns, and we're gonna show the labels and as well the color of the sales. So now we can see that the level of details of our visualization is going to be based on the postal code, since it's going to bring us to the lowest level of details. Let's say that the requirements wants us to have the level of details of the city and not the postal code. So there is 2 ways to do it. Either we're going to go and remove the postal code from the view over here. So with that, we got the level of details of the city. But now let's say that I still want to bring the postal code informations to this visual as a details for the users. So I cannot just drag and drop it, put it here. It's going to split the data, right? You can see here Paris, we have 2 values. So instead of that, we can use the attribute functions in Tableau if we still need to present the postal code informations in this visualization. So as we learned before, we can go over here and quickly switch it to attribute, or we can make it globally to reuse it in different worksheets. So let's go and choose that. So we're going to go and create a new calculated field. I'm going to call it attribute postal code. The function is very easy. It's going to be only the attribute and accept only one field. It's going to be the postal code, and it should be a dimension. So that's it. The calculation is valid. Let's go and hit OK. So with that, we got a new calculated field, a new dimension. Let's go and bring it to the view and remove the postal code. Now we can understand quickly from the view that the postal code and the city, they are almost at the same level of details. As you can see, we have always values, but only 2 countries where we have the asterisk. So we have the Paris and the Portland. So with that, we understand the relationship between the postal code and the city. They are almost at the same level, but sometimes we have more details. So in Paris, we have here two different values for the postal code and as well for the Portland. Now, in order to show those details for the users, either we can leave it as like a field over here as a header, or a better way, in order to save some spaces in the visualizations and not show a lot of headers, we can show it in the tooltip. In order to do that, we're gonna drag our field and drop it on the details, and then we have over here this option to configure our tooltip. Let's go inside it. Now, as you can see, we have four informations: city, country, sales, and our new field, the attribute postal code. But I would like to rename it in order to make it easier for the users to read it. So it's going to be the postal code informations. Let's go and hit OK. And now, as the users are mouse hovering on those informations, you can see that we have more details about the city. We have the postal code informations inside it. And if we have multiple values like in Paris, we're going to have the asterisk. I usually explain it for the users. If you find the asterisk, it means we have more details about the aggregations, which may raise the curiosity for the users to go in more details analysis about the postal codes instead of the cities. And with that, we are presenting the postal code informations, even though that's our level of details in the visualizations is the city. So this is very common use case for the attribute, where you can present more details for the visualizations, even if you have a very high aggregated data as a view. And for that, we use the attribute function in Tableau. But sometimes we end up like in most of the situation that the users want to see those informations. They want to see those postal codes and the sales informations for them. In order to do that, we do the following. We go and create a new sheet. And this time we're going to create a view where the postal code is the level of details. So all what we need is the postal code and as well the sales. So drag and drop the sales to the view. Let's just make it a little bit bigger to see the header informations. So that's it. Let's call it sales by postal code. So this view going to be now embedded in the original view. In order to do that, we're going to go back to our view where we have the city as the level of details. Now we want to do an embedded worksheet inside this view, inside the tooltip. So let's go to the tooltip over here and let's have a new line. And then we're going to go to this menu over here, the inserts. The first option, we have the sheets. So Tableau is going to show us all the sheets that we have in this workbook. It's going to be the last one, sales by postal code. So let's go and hit on that. Now we have embedded another worksheet inside the view using the tooltip. So that's it. It's very simple. Let's go and hit OK. So now let's go and mouse hover on those cities. As you can see, we have now a table or a view, small view inside the tooltip. So if you go to Paris now, we see now the two postal codes and as well the sales of those postal codes. So this is how I usually do it as a next step if the users want to see more details. But of course, this needs more calculations and more resources in Tableau to put one view in another one. If the users are happy with the asterisks, then stay with the attribute. But if they need more details, then you have to create another view and then put it inside the tooltip. Alright guys, so that's it for the first use case. We use the attribute to show more details for the users if we have a high aggregations in the view, and we use it usually in the tooltip. Alright guys, so now let's move on to the second use case where I usually use the attribute functions in my project is to check the data quality inside the data sources. Usually if you are working with the data, you have some expectations about the data quality, and if you have any suspicions, we can use the attribute functions in order to investigate the situation. For example, let's say that the expectations in our data to have only one country for each customers. So the data should not allow for some reason to have multiple countries for each customers. If you are skeptical about this information, or we want to check the quality of the data that we get, we can use the attribute functions like this. So we can go, for example, and take the customer ID, we can take the first name, last name, but now we would like to check the quality of the country. But since we have a lot of data inside our data source, it's going to be really hard now by just checking the values to understand whether we have multiple values for each customers or is it one-to-one relationship. Instead of that, we can go and aggregate the country using the attribute function. So let's do it this time by the quick way. So right click on the country and let's apply the attribute function. At the start, you might see, okay, nothing is changed, but now instead of quickly to validate the data, we can show it as a filter. So right click on the country over here and show filter. So now on the right side, Tableau going to show us all the possible values that could happen to this view. So here we have the asterisk. We have France, Germany, Italy, and USA. Of course, what is interesting is the first one. So I'm just going to remove everything and select the asterisk. Now we can see as we selected the asterisk, we don't get any data. This is perfect. That means the data quality inside our data is perfect and we have exactly one country for each customers. But if we start getting data from the asterisk, it means we have multiple values for each customers, and we can investigate this situation. So this is one-time analysis for our data to check the data quality. But let's say in the next day or the next month we got a lot of new customers and we want always to check those informations, we can go and make data quality dashboards for us or for the users to check whether our expectations is correct. Only selecting the asterisk, and we can explain that we expect that this view is going to be always empty. If this view is not empty, then we have a data quality issue. And we can add this information in the title. We can call it data quality check. Then it's about the multiple countries, and this is expected to be empty. So if it's empty, then everything is fine. So that's all for the second use case for the attribute function in Tableau. As you can see, it's really handy for the project, right? To understand your data, to do data quality checks and so on, or as well to show more details for the users inside the tooltip. Alright guys, so that's all for the attribute function in Tableau, and with that we have covered many important functions under the category aggregate calculations. Next, we're going to start talking about the LOD calculations in Tableau. They are really interesting and important to understand. Alright everyone, so now we're going to talk about the third type of Tableau calculations. We have the LOD expressions or LOD calculations. It is another type in order to aggregate the data in Tableau, and here we have only three functions. We have fixed, include, and exclude. And as usual, first we have to understand the concept behind them, then we're going to have enough examples in Tableau. So let's go. Alright guys, so now we can understand when do we need LOD expressions in Tableau using this very simple example. So let's say we are building a view where we have the category informations and the product name, and now we are showing the total sales for each product. And now by looking to those two dimensions, you can understand that the product name is controlling the level of details in our view. So we have 5 products, and with that we got 5 rows. So the product name is splitting the rows of this table. But now we come to the issue, if you want to show in the same view, in the same dimensions and setup, you want to show the total sales for each category. Well, we cannot do that as long as we have the product name inside this view, because the product name is splitting the view into products. So in order to show the total sales for each category, either you have to remove the product name from the view, so by just drag and drop it away, you can see now we got the total sales for each category. But if you say, wait, we need to have the product informations in the view, we cannot drop it. So let's go and bring it back over here. So if you need to have the product name and you still want to have the total sales for each category, we have to use the LOD expressions. So exactly in this situation where we need the help of LOD expressions to control the level of details of our aggregations. So now let's go further and understand how LOD works. Okay, so now we're going to have quick facts about the LOD calculations. First, LOD calculation is going to go and aggregate the rows of the data source at the dimension level that we specify inside the calculation. So that means the dimension of the visualizations will not control the level of details. This time we're going to have the level of details of the LOD expressions. And the LOD calculations, like the aggregate calculations, Tableau going to go to the data source in order to query the data there and then bring the result to the visualizations. And the calculation gonna happen on the fly. That means Tableau gonna execute the calculation only if you bring the field to the visualizations. So Tableau will not pre-calculate and store the informations inside the data source. So again, how it works, the visualization is gonna send a query to the data source, and the data source is gonna answer with the results. So this is how Tableau execute the LOD calculations. Alright everyone, we talked about the level of details many times during the tutorials, but now let's understand what do we mean exactly with the level of details. Let's say that we use in Tableau only the measure without any dimensions. With that, we're going to be at the level 1, and we will get, for example, the total sales if you are using the measure sales. So Tableau going to go and summarize all the sales inside the data source and present it as only one row, one value. So without using any dimensions, we will get the highest level of aggregations. Let's go to the next level. Let's say that we use a dimension like the category. In our small data source, we have only 2 values. So Tableau gonna split this one value into 2 values. So here we can see more details about our sales. It's not only one value, now we have it as 2 values. So that means this dimension gonna split our view into 2 rows. Moving on to the third level, let's say that you use the country. Inside the data source, we have 3 countries. That means we're gonna have 3 rows. And we have more details now about the sales. So as you can see, the sales gonna split into 3 rows. So that means the level of details of the category is different from the country. In the category, we have 2 rows. In the country, we're going to have 3 rows. Moving on to the last level, if you bring the order ID to the visualizations, you will get the highest level of details. It is exactly the level of details that we have inside the data source. We don't have in our data model any dimension that's gonna break these rows to more details. So we are now at the bottom, at the highest level of details, and we're gonna have exactly 15 rows because we have 15 orders. So that means each of those dimensions gonna go and break the visualizations into different level of details. The category gonna break it into 2, country 3, product name 4, order ID gonna break it into 15 rows. So that means the level of details is the highest at the order ID, and it's gonna be the lowest if you don't use any dimensions. And the opposite if you are talking about the aggregations, the highest level of aggregations if you don't use any dimensions, and you're gonna get the lowest level of aggregations if you're gonna use a dimension like the order ID. So with that we understood, each dimensions brings us to a different level of details. So this is what do we mean with the level of details in Tableau. Alright guys, now we're gonna go and understand the LOD functions in Tableau, but first we can split those 3 functions into 2 categories. The first one gonna be the static calculations, where we have only one function, it is the fixed. The second one we have the dynamic calculations, and here we have the 2 functions, include and exclude. So if you want to have a fixed or static calculation, you're gonna use fixed, but if you need more dynamic, then you have to use include and exclude. The dimensions inside our visualizations or in the LOD expressions define the level of details, and each dimension has different level of details. For example, the category has only 2 values. That means the level of details here is very low compared to the order ID where we have the highest level of details. So let's say that our current level of details inside the view is the country. So we have the level 3. We can use the LOD expressions in order to bring the calculations to a lower level of details. And we can use the exclude or the fixed function to bring it, for example, to the level 2 at the category. But now in order to present the calculations in the current view, what can happen? The value is going to be duplicated or replicated. Like we have seen in the last use case where we have the table and we duplicated or replicated all the values. Or we can use the LOD expressions to bring us to a higher level of details, like using the include or fixed. But now if we want to bring back the calculations to the current view, we have to do aggregations, like we have done the average number of customers for each category, since the customers has higher level of details than the category. So you have to pay attention to the dimensions that you are using inside the LOD calculations. If it's going to bring the aggregations to a higher level of details, then you have to focus on the aggregate functions that you are using in order to bring the result to the current level of details in the view. So that means we have always to aggregate data in order to go back to a lower level of details or to higher level of aggregations. So always here we have to use an aggregate functions in order to come back to the current level of details. But if we are on above, it's easy, it's gonna just duplicate the data and replicate it. Alright guys, so I hope that was clear. This is one of the most complicated concepts that we have in Tableau if you compare to all other concepts. Alright guys, now we're gonna go and understand the syntax of the LOD expressions. They start with the function name, so either it's gonna be the fixed, include or exclude. After that we have the double points, then we have to define the aggregations. It's like the aggregate calculations, something like sum of sales, average of sales, max, min, and so on. But the most usual aggregation that we use here is the sum of something. Let's have a few examples. We can go with the following, like we say fixed, then we don't specify any dimensions, then we specify the aggregations. So here we have in this example the sum of sales. Now think about the LOD expressions as you are building any view in Tableau. You always have to specify the dimensions and measures the aggregations. So here we are telling Tableau to do the sum of sales without considering any dimensions. Now let's go and add a dimensions inside the calculation, like for example the category. And here again, the same analogy. It's like you are building view from the dimension category and the aggregation sum of sales. And of course, you can go and add more dimensions like the category and the product name. The same analogy. We have 2 dimensions in the view, category, product name, and then we have the sum of sales. And now, of course, we can go and add more dimensions like the category, comma, product name. So the same analogy, we are adding 2 dimensions to the view, category, and the product name, and the aggregation is the sum of sales. And of course, we can go and use another functions like the include or exclude in those examples, or another aggregations like the average of sales and so on. So as you can see, building an LOD expression is very similar as you are building any view, you have always to define the dimensions and as well the aggregations from the measures. So that's all about the syntax of the LOD expressions. Alright, so there are two types of level of details, LOD. The first one is the one that we define inside our visualizations, we call it LOD Viz, and the other one that we define inside the calculations, we call it LOD expressions. So now let's say that inside the visualizations, we have two dimensions, category and country, and we have the sales. And now on the right side in the LOD, if you go and use the fixed function, so let's say that we have the fixed category, sum of sales. So what we have done here is exactly like you are building any other view. You need always a dimension and as well an aggregation. So with that, Tableau gonna go and let's say internally gonna create a hidden view with the dimension category and the aggregation sum of sales. So here, since we said it is a fixed function, Tableau will ignore the dimension that we have on the view. So it's going to work completely independent from the dimensions that is presented in the view. So that means the calculation going to be very static, and doesn't matter what you're going to do in the visualizations, nothing going to change in the calculation of the LOD expression. So what do I really mean? Let's say that in the view you have added a new dimension, let's say the product. Now you have made a change in the visualizations. We have now three dimensions: product, category and country. But the LOD expression will not change at all. It's gonna get exactly the same results. It's gonna have the category and the aggregation sales. So this is the main purpose of the fixed function, to make it independent from the dimensions that we have inside the view. So everything gonna be static, and this is exactly the main difference between this function and the other two, include and exclude. So as you can see, building the LOD expressions, it's very easy. It's very similar as you are building visualizations in Tableau. As you are dragging the dimensions and the aggregations, here instead you have to define it inside the calculation, and always we have to define the dimensions and the aggregations. So it's really simple once you understand it. Now let's move to the next one, to the exclude. Alright everyone, so now back to our view where we have the product name in the visualizations, and we cannot use the aggregate calculations in order to show the total sales by category. In order to solve this, we're going to use the LOD expressions using the fixed function. So let's go and create a new calculated field. So we will call it sales by category. And now we're going to use the fixed function. So let's start typing fixed and use this suggestion from here. And now next we have to define the dimension. Since we said sales by category, then we need the category. So let's add the dimension category and then double point, and the aggregation going to be the sum of sales. And at the end we have to close the brackets. So as you can see, it's very simple. We have to define the dimension and as well the aggregation that we need in the visualizations. So let's go and hit OK. But as usual, we will get a new calculated field on the measure, and it's going to be calculated on the flies. That means Tableau will not go now and store the results in the data source. So let's go and check the results. Drag and drop it to the view over here. So now we see in the results, we have the sales by the category. We are ignoring the dimension product name, and it is based completely on the dimension category. And when I usually work with the LOD expressions, in order to understand it, I always imagine that Tableau is creating a separate view in order to calculate the LOD expressions, then add it to the current view. So let me show you what I mean with that. So let's go and open again our calculated field. And on the right side, we have over here the data source information. Since Tableau gonna go and query those data, so we are saying fixed category. So that means we can grab the dimension category, and inside it there are two values. We have the accessories and the monitor. So next we have the sum of sales. This is the aggregation. So Tableau gonna grab the sales and start doing the aggregation. So it's gonna go and summarize all those values for the first sections for the accessories, and we will get the total sales of the accessories. And then Tableau gonna go and summarize all the sales for the second category, and with that we will get the total sales by monitor. So the output of our calculation, the LOD expression, gonna look something like this. As you can see, the level of details in the LOD expression is completely different than the view. So here we have only 2 rows, and in the view we have 5 rows. The next step, Tableau gonna go and merge those results to the view. So we have the first 3 products belongs to the category accessories. That's why we are seeing the values, the total sales from the accessory in the view. And then the next 2 products belongs to the category monitor. That's why we are seeing the total sales by the monitor. So this is how I usually do it in order to understand the LOD expressions if things get complicated. Now, one more thing about the fixed calculations, we say that it is static, it is fixed. So it doesn't matter what I'm presenting in the view, we will always get the same results and nothing gonna change in the LOD expression. So what I mean with that, let's go and change a few stuff. Let's take the product name away. You can see we still get the same values. Let's go and add, for example, the country to the view. So let's go to the locations and just add the countries. As you can see, nothing gonna change. The LOD expression gonna have exactly the same values and it is static. Alright guys, so that's how the fixed LOD expression works in Tableau. Alright guys, so now we have the following use case. I would like to create a histogram to measure the customer's loyalty. That means I would like to have a data distributions of the number of customers distributed by the number of orders. So I would like to understand here what are the number of orders that the majority of my customers are ordering. So that means I would like to understand the behavior of my customers. So that means in order to build such a thing, we need two measures, the number of customers and the number of orders. Well, before we have learned how to build the histograms, but only from one measure. So if you have two measures, this time we have to go and create LOD expressions. So now let's do it step by step in order to learn how to build such a visual. Alright guys, so first let's understand the data that we have. Let's show the number of orders for each customers. So let's go to the customers over here. We are at the big data source. Then let's take, for example, the customer ID. With that, we're going to have a list of all customers inside the data source. And then let's go to the orders and grab the order count. So with that, we got the count of orders for each customers. And now let's go and sort the data. So we can see we have only one customers with the highest number of orders, 29. Then we have 3 customers that ordered the same amount. So we have 28 3 times. So 3 customers ordered the same amount. Then we have 1 customer that ordered 26. Then we have over here 5 customers that ordered the same amount. So we have 25 orders for those 5 customers. So now since we have two measures, the number of orders and the number of customers, we have to turn one of them to a dimension. So I'm going to be working now with the number of orders to turn it to a dimension. So we want those values, the 29, 28, 26, 25. In order to do that, we can go and create an LOD expressions using the fixed function. So let's go and create a new calculated field. We're going to call it number of orders per customer. We're going to go and build something very similar to this view using the LOD expressions. So we're going to start with a fixed function, and then our dimension going to be the customer ID, like in the view. And then our aggregation going to be the count of orders. You can go with the distinct if you are not sure whether there are duplicates inside the orders, but I would stick with the counts. And then we're going to have the order ID, and then let's go and close it. So with that, the calculation is valid. So we just built exactly like this view. Let's go and hit OK. So now with that, we got our new field over here, the number of orders. Let's go and check the results. It's going to be exactly the same data that we have inside our view. But this time we have an LOD expression where we have more control in this measure. So now we're going to drop everything from the view. We just need the new calculated field. And now let's go and switch it to dimension in order to have distinct values. And then move it to discrete. So with that, we got something very similar to the bins, right? Here we have a distinct values from the number of orders. Now what is missing is of course here the number of customers in order to have histogram. So let's go to the customers counts over here and just drop it on the rows. And with that, we got exactly what we want, the data distributions of the number of customers. So as you can see over here, for example, we have 3 customers that ordered 4 times. And here again, we have only 1 customer that ordered 29 times. If you remember the example, and then we have here those 3 customers that ordered 28 times. So with that, you can understand quickly the behavior of the customers by just checking the view. We can understand that most of our customers are ordering between 11 and 16, which is really good. Like we don't have a lot of customers that are ordering only once. So the left side over here is really low, which is very good. And of course, now we are summarizing all the data that we have inside the data source, the 5 years. And now you might have the question, does the behavior of the customer change over the time? In order to answer this question, you have to bring the time. So we have to bring the order date. Let's drag and drop it to the rows over here. And now we can see very quickly that the behavior of the customers are not changing over the time. So as you can see, the histograms looks identical, right? So most of the customers are ordering between 11 and 15, and that's over the years. And we cannot do such analysis without the LOD expressions, so you can see the power of LOD. Okay, so in the visualizations, we're going to have exactly the same view with the 2 dimensions, category and country. But now in the LOD expressions, we're going to use the exclude, where we're going to have exclude category, sum of sales. So now what we are telling Tableau is to go and exclude the dimension category from the visualization. So that means in the LOD expression on the right side, we're gonna get all the dimensions from the visualizations, and we will exclude now the category. So it's gonna remove the category from the dimensions, and that means on the LOD expression now in this example, we have the country that's gonna control the level of details in the LOD expressions, and Tableau gonna do the aggregations again depending on this dimension. So that means the exclude function will always remove the dimensions that is specified in the calculation. And here the big difference between the exclude and the fixed. Exclude is depending on the dimensions that we have in the view. So let's say that we have added in the view another dimension. So now we have product, category, and country. What can happen to the LOD expressions? Tableau gonna take all those dimensions and will only exclude the category. That means the calculation now gonna depend only on the product and the country. So as you can see, it is very dynamic and it depends on the visualizations. So the exclude will always react to the dimensions that are specified in the visualizations and gonna remove the dimensions that we specify in the calculation. Okay, moving on to the second LOD function that we have, the exclude. So let's say that I would like to have the total sales inside the view, but I would like to ignore the dimension category. So in order to do that, we can use the exclude. Let's go and create a new calculated field, and let's call it sales exclude category. So we start with the function exclude, so let's select that, and then we're gonna have to specify the dimension that should be excluded. It's gonna be the category. After that, as usual, we have to define the aggregate calculation. It's gonna be the sum of sales, and let's close the brackets. So it's very simple. We are telling Tableau to ignore always the category from the calculations. So everything is valid. Let's go and hit OK. And as usual, we will get our new calculated field in the data pane. Let's go and drop it on the view in order to check the results. So now if you check the new results, you can see we got different numbers from the sales by category or the original sales. So what is going on over here? And now since we are using the exclude function in Tableau, the LOD calculation is going to be depending on the dimensions of the view. So let's open again our calculated field and let's see what Tableau gonna do. So Tableau gonna depend on the dimensions that we have inside the view. So we will have in the LOD calculations the country and the category, but since we are here saying okay, go and exclude, go and remove the category, so Tableau can remove the dimension category, and with that we are left only with the dimension country. So since we here have like duplicates and we have only 3 countries, so at the end in the LOD expressions, we will have 3 rows. So now what Tableau gonna do, gonna go and find the sales, the total sales for each countries, and the data source gonna be split into 3 groups for each country one. So we have France, Germany, and USA. So that means Tableau gonna go, for example, for France and go and summarize all the sales for those 3 orders and put the results at the output, then goes for the same as well for Germany and take all those sales, summarize it, and get as well in the results the total sales for Germany. And then we have for the USA those 4 orders, and Tableau gonna go and summarize the sales for that. So with that, the output of the LOD expression gonna look like this. We have the country and the total sales of countries. So now if you compare it to the view, to the results that we have, as you can see, as we exclude the category, we're gonna have the total sales for each country. So here France, we have 172, and as well for the second category, we have France, we will get exactly the same total sales. And the same thing gonna happen for Germany, so we will have exactly the same values in both categories. So for Germany, we will get this value, and as well for the monitoring in Germany, we will get this value. So as you can see, once you understand what is going on in the background, you will understand the numbers in the view. So as we say that the exclude is dynamic, it is not like the fixed. We will not get always those results. It's really going to depend on the views, on the dimensions that we have in the view. Let's take, for example, let's add another dimension to the view. Let's go and get the customers. So let's go to the customers, take the first name, and let's drop it over here. So now if you look closely to the data, you can see the fixed, those numbers, nothing's changed inside it because it's always fixed to the category dimension. But the exclude this time, they have different numbers. So if you go and compare what do we have at the start, at the total sales for countries, those numbers, you don't find it anymore in these sales over here. And that's because we have added a new dimensions. We don't have only the country, we have as well the first name of the customers. So that means now we have in the LOD expressions 2 dimensions, the country and the first name. So the result, the output of the LOD expression gonna look like this. We have 2 dimensions, country and the first name. We don't have the category, we exclude it, we remove it from the view. And then we have the total sales for this combination of dimensions. So the total sales for George from France, total sales for Maria from Germany, and so on. And those numbers are exactly the same that you are seeing in the view. So as you can see, the exclude function is dynamic and depends on the dimensions that are presented inside the view. So this is how it works. Now let's move to the next one. We have the include. Alright, so now let's move to the include function. It is exactly the opposite of exclude. So we're going to have the same example. In the visualizations, we have the two dimensions, category and country. And now we're going to say to Tableau, include customer dimension, and we're going to have the same aggregation, the sum of sales. So now what we are telling Tableau with this calculation is to add one more dimensions to the visualizations, to add the dimension customers to the two other dimensions that we have inside the visualizations. So here again, it's very dynamic. Tableau going to take the dimensions that are presented in the visualizations, the category and the country, and add to it a new dimension, the customers. And the function include is very similar to the exclude. It is dynamic, so it is depending on the dimensions that we have inside the visualizations. So again, the same example, if we go and add one more dimension, the products, we will end up having 3 dimensions in the visualizations, and Tableau in the LOD expressions gonna add one more dimensions to the expression where we're gonna have at the ends 4 dimensions: customers, product, category, and country. So that means in include function, we are saying do the aggregations in all dimensions that we have inside the visualizations plus one more dimension that comes from the calculation. So it's really easy, right? So now to summarize, the fixed function is very static. It doesn't care about the dimensions that we have inside the visualizations. It is completely independent. So it's gonna stay the same as you are changing the visualizations. But the exclude and include, they are depending on the visualizations. So exclude gonna go and remove one dimensions from the dimensions that are presented in the visualizations, where include gonna go and add plus one more dimension to the dimensions that are presented in the visualizations. So with that, we have now understanding how those 3 functions works in Tableau. So now we're going to go back to Tableau in order to practice those 3 functions. So let's go. Alright, so now we need more attention about this function, the include. It is more difficult than the exclude and fixed. So let's have some coffee. Let's go. Alright, so as we learned before that each dimensions has different level of details. For example, the first name has more details than the country or the category. So now comes the issue, if you want to remove such a details from the visualizations, so you want to remove the customers' names and you want to stick only with the category and the country, but still you want to introduce an aggregations that has to do with the customers, with the dimension that has a lot of details. So for example, we want to bring here an aggregation that shows the average sales of customers for each country and category, but without showing the customer's informations as a dimension. So let's go and remove the first name from here. So we don't have here any customer's informations, but still we want to bring the aggregations to the customer's level by calculating the average sales of customers. In this case, if your aggregation is based on a dimensions with a high level of details like the customers or the order ID, then you have to use the function include. So let's see how we can do that. Let's go and create a new calculated field, and we're going to call it average sales of customers. We're going to use the function include. So let's select the include. Now we have to say to Tableau which dimension can be included in the view. So currently we have the category and the country. We would like to add the first name, or you can add the customer ID, doesn't matter. So let's add the first name, and then we have to add the aggregations. So this time we're going to use the sum of sales. Now you might ask, why do we have the sum of sales? We are talking about the average. Well, the average is going to be the second aggregation that we're going to do it on top of this LOD expression. First, we have to summarize the values that we have inside the data source, and then we're going to do the average on top of it. So we're going to do it step by step, don't worry about it. Then we have to close the brackets like this. So as you can see now, the calculation is valid. Let's go and hit OK. So with that, as usual, we get a new calculated field. Let's drag and drop it to the view. We still are not there because here we have the average sales of customers, but the function that is used in Tableau is the sum. So we have to go and switch it to the average function. So let's go and do that. So with that, we got the average sales of customers for each category and country. So now we're going to see step by step how Tableau did the execution of the include. So the include going to depend on the dimensions of the view. So we have here the category and the country. That means Tableau going to start something like this. We have the category and the country. The next step, Tableau going to go and check the LOD function. So let's go and open it again. So we are telling Tableau now, go and include the first name to the dimensions that are displayed in the view. So Tableau gonna go and grab those informations, the first name, and present it in the output. So we will have 3 dimensions: first name, category, and country. So we're gonna have something like this. So now if you compare the number of rows of the LOD expressions with the view, you can see that we have now more details in the LOD expressions since we added the first name. So here we have around 8 rows, but in the view we have 6 rows. So the level of details of the LOD expressions is higher than the view. Tableau gonna go to the next step and say, okay, we have to have the sum of sales. So we're gonna have the sales as well over here, and Tableau gonna go start aggregating the rows. So for example, first we have George, accessories, and France. It's gonna be only this row over here. We don't have it anywhere else. So we're gonna have the 91. Then we have Maria, accessories, Germany, and for that we have 3 rows. So Tableau gonna go and aggregate those 3 rows in the outputs. We will get something like this, and so on. So Tableau gonna go and start summarizing those values based on those 3 dimensions. And at the end, we will get in the output something like this. So with that, Tableau calculated the sum of sales by including the first name to the dimensions that are presented in the visualization. And here we come to the issue where we have in the LOD expressions more details than the view. So in order to bring those results to the view, we have to aggregate it again. So we have to either summarize it or do the average and so on. So we cannot bring those details over here without doing any aggregations. In this example, we want to find the average of customers for each category and country. That's why we have used the average function. So that means if we are using the include function or you have more details in the LOD expressions, we have to aggregate the data in order to bring it to the visualizations. But in the other hand, if you are using exclude or fixed and the output of the LOD expression has lower level of details than the view, then what's gonna happen? We're gonna have duplicates. For example, you can see over here, sales by category. You can see we have duplicates. So it doesn't matter which function we're gonna use, summarize or average, we will get always the duplicates. The same thing for the exclude. We had lower level in details in the expressions compared to the view. That's why you can see duplicates. We have the same numbers over here, those 3 rows, they are like repeated over here for the second category. So this is the effect of the LOD expressions. If the level of details in the expression is higher than the visualizations, then we have to aggregate the data. But if the level of details in the LOD expressions is lower than the view, then what can happen? We're gonna get duplicates. So now back to our example, Tableau gonna go and find the average of those values. So the first value is going to stay the same because we have it only as 1 row, so it's going to stay the same. But now for those 2 rows, as you can see, German accessories, Tableau going to go and find the average of those 2 values. We will get 954. And then for the next row, we have accessories USA. In the output, we have only 1 row. That's why the average going to be exactly the same. The same goes for monitor France, the same value. But the next value, we have monitor Germany. Here we have 2 values, so Tableau can go and find the average of those 2 values, and we will get 433. And for the last one, we got only 1 value. That's why we got exactly the same number. Yeah, as you can see, if you get more details as a result from the LOD expressions, things get more complicated, and you have to be careful which aggregations you are using in the visualizations. All right, guys, so with that, we have learned how Tableau can execute those 3 functions step by step. So now next, we're going to go and learn real use cases of those functions. Alright everyone, so now in this use case, we want to compare the sales of all categories to the sales of a specific category, like here selected one, the tables, in order to understand how the sales of the other categories are doing to this specific category. So in order to build such a view, we have to use the power of LOD expressions. This time we're going to use the exclude. So let's learn step by step how to create such a view. Alright, so now let's start with the first step where we want to show the sales by subcategory. So this is the easiest one. Let's go and grab the subcategory to the rows, and let's take the sales to the columns, and then we're going to go and sort the sales. So let's go and do that. Now our task is to go and find the differences between each subcategory with a specific subcategory, the tables. So for example, we're going to go and find the difference between the sales of phones and the sales of tables. So that means in order to find the differences in each row, we need 2 measures. The first measure is going to be the sales of the current category, like for example, the sales of the phone. And the second measure, we need the sales of the tables. So here we need the sales of the tables to be as well at the same row. So the first measure, we have it already, right? We have here the sales for each category, but the second one, we don't have it yet. So we need to have for each row the sales of the tables. In order to do that, we're going to go and create a new calculated field to have these tasks. So let's go and create a new calculated field. So let's call it sales of tables. What you want to check now is whether the subcategory, the current one, is tables. If yes, then show the sales. So we're going to use the if statements. Then we want to check the subcategory. If it equals to tables, you should write it exactly like the data that we have inside the data source. So what's going to happen? We want to show the sales. Otherwise, do nothing. So we want to have nulls if the subcategory is not tables. So what we are doing now is isolating the sales of the subcategory tables. So let's go and hit OK, and let's go and bring it to the view over here. So with that, as you can see, we have isolated the sales of the tables in this new measure, but we still have a problem that we would like to repeat this value for each row. So as you can see, we have it only if the subcategory equals to tables. So now in order to repeat this value for all the rows, here comes the trick or the magic of the LOD expression exclude. As we learned before, the exclude gonna go and repeat the values, right? So we can go and use this trick. So what we're gonna tell Tableau is that imagine that in this view there is no subcategory. So what's gonna happen? This measure gonna be repeated for all rows. Let's go and do that. So let's go and create a new calculated field. So we're gonna call it exclude subcategory. So now we have to use the nested calculations, because if you put everything in one calculation, it's gonna be really complicated. So now we want to tell Tableau, imagine that we don't have subcategory in our view. So exclude subcategory, and the aggregation gonna be the sum, but this time of the new measure that we created for the tables. So sum sales of tables, and then we have to close it. So something like this. So we are telling Tableau, exclude the subcategory from the view and do the aggregations. So let's see what's gonna happen. Hit OK and drag and drop to the view over here. So as you can see, since we have only one value and we are ignoring completely the subcategory, we will get the same value repeated for each rows. So now we have all what do we need to find the differences, right? We have the sales of each categories and the sales of specific category, the tables. So now we're going to move to the last step, where it's going to be the easiest part, where we want to find the difference between those two measures. So we're going to go and subtract them. Let's go and create a new calculated field. Let's call it difference. And then we're going to subtract the first value. It's going to be simply the sum of sales. This is going to be the first value that we have over here. Then with our new measure, it's going to be the sum of our exclude function. So exclude subcategory, and that's it. Let's go and hit OK. And let's drop it to the view. So with that, we solve the task. We have the differences between the sales of each category and the sales of specific category, the tables. And of course, you can see the table is going to be 0 over here because we are subtracting the sum of sales with the exactly the same sales. So it is a little bit tricky, but if you understand how the LOD expressions works, you can really do such analysis. So now let's go and drop everything from here. We don't need those sub steps. So I'm just going to remove them. And now, of course, we can add the coloring over here. So let's go to the measure on the right side and let's take the measure to the colors. And with that, we can see nicely the differences between the subcategories and the tables. So now if you'd like to highlight the tables, since it's our main category where we're comparing all the others to it, we can make the use of the sales of tables. So let's switch to this measure over here to the sum of sales and the marks. And then let's take the sales of tables and put it on the colors. And with that, you are highlighting the main subcategory. So with that, we have made really complicated analyses using the LOD expressions. Alright everyone, so now we're going to talk about the last type of calculations that we have in Tableau, the table calculations. And here we have different functions like the running, window, rank, first, last, index, lookup. We're going to talk about all those functions in this tutorial. So as usual, first we're going to understand the concept behind the table calculations, then we're going to go back to Tableau in order to start practicing. So let's go. The first question is, what are table calculations? Well, they are calculations that's going to be executed or performed after the aggregation is done on the visualizations. So they're going to like aggregate the aggregations in Tableau. And it's important to understand the level of details. It's going to be depending on the visualizations. So that means here again, the dimensions in the view going to control the level of details. And now to the big difference between the table calculations and the others, the calculation is going to be performed on the data that we see in the view. So Tableau will not go to the data source and query the data. Tableau going to query the data that is presented in the view. So that means the view going to be querying the view itself. It's going to send a query to the data inside the visualizations, and the view going to return the result back to the view itself. So we are not going back to the data source. Everything going to be queried inside the view. And the other three type of calculations, like the aggregate calculations, LOD, and row level calculations, they always gonna query the data from the data source and bring the result to the view. Only this type of calculation gonna query the data in the view. Alright guys, in order to create table calculations, we have to define two things. First, the scope. Second, we have to define the directions. The scope means which data can be included in one calculation. For example, we have the following view. It looks like a table, right? So we have here rows and we have multiple columns. But here we can see that our data is split by groups. Each group can be defined by the dimension quarter. So we have the Q1, Q2, Q3, and Q4. So now the first option that we have is the whole table. That means the calculation can include everything inside this table. It will ignore any partitions that we have inside this table. So it's going to start from the first value and it's going to end up by the last value. Moving on to the next scope or to the next option, we have the pane. This time the calculation is going to focus on a smaller scope. This time we're going to focus on the partition or the group of data, which is defined by the quarter. So that means the table calculation is going to be done for each group separately. So we're going to have for those 3 rows calculations, then we can move to the second group, to the third group, and so on. Moving on to the last scope, we have the cell. So it's gonna be only one value inside the view. The scope gonna be very small, including only one individual value. So here we have to define for Tableau the scope of the calculations. Is it going to be the whole table, or only the pane, only the group of data, or only one cell? Alright, the next thing that Tableau needs from us is the direction of the calculations. How the calculation going to move through our table. So here we have 4 different options. The first one going to be down. That means we're going to start from the top value and we're going to move down until we reach the bottom. And that's of course going to depend on the scope, whether we are running the whole table or only a group of values like we have in the pane. And in this example we have the table down. That means we are processing all the values in one calculations from top to bottom, then it's gonna reset and move to the second column, and we're gonna do the same thing for the next year. So that means this time the calculations is moving through the columns in one go. So it starts from the first year and it end up with the next year, then it's gonna reset and start for the next row and so on. So we are moving from left to right. So those 2 methods are the basics. Either you're gonna move down or you're gonna move right. The next 2 directions, it's gonna be mixing those 2 methods. So the first one gonna be down then across. So that means first we have to go down through the table and then we have to go across. So it's gonna start from the top first, then go to the bottom, but this time it will not reset and move to the next column. It's gonna continue doing the aggregations. So it's gonna go to the right across, then it's gonna go move again from top to bottom, then across, top to bottom until we reach the last value. So that means here we don't have any resets. It's going to continue the calculations through all values. It's not like the first 2 methods where we have resets for each row over here or for each column. This time the starting value going to be the top left and the last value going to be the bottom right. Moving on to the last direction that we have, I think you got it already. It's exactly the opposite. First we do across, then we're going to do down. So here again there is no resets. We're going to start with the first value on the top left, and then we go to the right first, then we jump to the next row, then we go to the right, we jump down, right until we reach the last value on the bottom right. So that means the calculation first is gonna move right and then it's gonna jump down to the next row. Alright, so as you can see, it's not that hard once you get it. We have 4 different directions and 3 different scopes that Tableau needs from us in order to create table calculations. Alright guys, in Tableau we have different methods on how to create table calculations, depend on the difficulty. The first method that we have is the quick table calculations. So as the name says, it's very quick and easy to create. So here we have a list of different table calculations and you don't have to configure anything. You just have to click on the function that you need and Tableau can do the rest. So here we have a very common table calculations like the running total, the difference, rank, moving average, and so on. The second method is going to be not that quick. We have to configure a few stuff, but still we are not writing any functions or any calculations. Still we are clicking around. But here we have more options and more control to configure the table calculations if you compare to the first one. The first one is just selecting the function and that's it. So here again we have very similar functions. We have the rank, running total, moving calculations. And then we can define different options like the scope, which dimensions can control the table calculations, and so on. Moving on to the last method on how to create table calculations, we can do it by creating a new calculated field and then use the functions that are used for the table calculations. And here we have a list of many functions that you can use in order to do table calculations, but they are a little bit harder if you compare to the first two methods in order to create table calculations. So as you can see, as you are moving from left to right, things get harder, but with that you are getting the full control and the full options. And next we will go back to Tableau in order to try those three methods, and we're gonna try a few functions that we have inside the table calculations. Alright guys, so back to Tableau, let's go to the big data source, let's go to the product and get the usual stuff. So we're gonna get the category, subcategory, and the cells as usual to the cells over here. So now I'm going to show you the different methods on how to create table calculations, and we're going to start with the first one. We have the quick table calculations, which is the easiest one. In order to do that, we're going to do it on the view, so it's going to be only locally available for this view. It's not like creating a new calculated field. So we're going to go to our measure over here, right click on it, and then here we have two options. The first one says add table calculations, and the second one gonna be quick table calculations. The first one is the middle one that I showed you previously in the presentation, where you have to configure different stuff, but the second one is the easiest one and the quickest one, where we can create table calculations with only one click. So now let's go and check the quick table calculations. If you go over here, you will find a list of different table calculations, and we can go over here and let's check, for example, the running total. So click on that, and here there is two things to be noticed. First, the numbers here changed because here we have different aggregation functions, and as well we have here a new icon in the measure. Tableau here wants us to quickly identify whether the measure is using aggregate calculations or a table calculations. So if you see the triangle, that means this measure is using table calculations. So as you can see, with only one click, we have created table calculations. Here we have the running total. Don't worry about it. I'm gonna explain it step by step later. Well, now you might say, you know what? We didn't define anything. The scope, the directions for the calculations. So how we can do that? If you go back to our measure, to the table calculations, right click on it, and you can find now we have more options once we convert it to table calculations. And exactly here, the computing using, we have those options. So here we can define the scope, table, pane, cell, and as well the directions. And as well, you can see that we have different options like clear table calculations if you want to remove it back to the aggregate calculations. So once you do that, you can see we got back our sum of sales without the icon. Well, that means we are not using anymore the table calculations. We are using now the aggregate calculations. So that's all for the first method, how to quickly create table calculations in Tableau, but we don't have a lot of options to configure. That's why we have the second method where we have more options to control the table calculations. But again, we're going to create it locally only for this view, so it will not be available for the data source. Alright, so before I show you how to do that, we're going to get one more dimension to our view. So let's get the years of the order date, and I would like to have only 3 years, so I'm going to show it as a filter. I'm just going to remove the first 2 years in order to have fewer data in the view. So now in order to create table calculations only for this view with more options, we're going to go back to our measure, the sum of sales. Currently it is an aggregate calculations, but we want to convert it to table calculation. So right click on it, and this time we're going to move to add table calculations for the first option. So as you can see, we have this small icon indicate that this is table calculation. So click on that, and we will get a new window here to configure our table calculations. So what do we have here? The first thing that we have to define is the type of calculations. So we have here a menu of different functions for the table calculations. Again, here the running total, the rank, differences, and so on. So let's stick with the first one, the differences from. So here we have to define for Tableau two things, the scope and the directions, and they are always together. They are not split as options. So the first one going to be table across, and Tableau here did really great job by highlighting how the calculation gonna work. So as you can see, Tableau here highlighting with the yellow color how the calculation is gonna be performed. It's just to help you to understand how it's gonna work. It's really great. So we have the table across from left to right, then we have the table down from top to bottom, and then we have the option of across then down, and as you can see, it's gonna affect the whole table since we move from the top left to the bottom right. Then we can define the other scope, like for example the pane down. So as you can see now, the scope is smaller compared to the table down. So now the table down include everything in this column, but the pane down can include only this group. So as you can see, our view is split to 3 groups based on the category. So we have the first group over here, the second and the third, and Tableau is highlighting the first group. So it is like a partition. And another option, we have the cell, where Tableau can highlight only one value, or we can define specific dimension to do the calculations. So here we have a list of all dimensions that we have inside the view, and you can go and select what the scope gonna be, whether it's gonna be the subcategory or the year of order dates. Then each function that we have has more specifications. For example, here, what are the values that are relevant for this calculation? Again, here, don't worry about it. I'm gonna explain how the difference work as well in Tableau. So here we do have to define whether it's the previous, next, first, and so on. So each function in Tableau has different options. So for example, if you go to the rank, you will find over here, we don't have now those previous, next, and so on, but instead we have different options to configure the rank. So each Tableau calculation function here has different set of options to be configured. All right, guys, so that's all for this method. As you can see, we got more options compared to the first one. Let's go and close this. And let's say that we are interested to have this calculation for all other worksheets. So we want to reuse it. In order to do that, we're going to go to our measure and just drag and drop it here on the data pane, and with that we got a new calculated field. So this time we are using the rank of sales, so I can go and rename it rank and sales, and with that we got a new field on our data pane and we can reuse it in different worksheets. Alright guys, so now we're gonna move to the last methods in how to create table calculations in Tableau. We're gonna go and create a new calculated field and use functions. So let's go and do that. We will start with the function index. So let's create a new calculated field. We can call it index. And the syntax is very simple. So start with index and that's it. We don't need to specify anything for this function. So as you can see, the calculation is valid. Let's click OK. And with that, we got a new measure, new calculated field. Let's go and check the results. So I'm just going to drag and drop it on the view. So what this function does is it's going to return the position number of the current value. So that means the first position in this view going to be the first row as we are moving from top to bottom. So this is going to be the position number 1, position number 2, 3, 4, and so on until we get the last value as the last position. So now you might notice that we are calculating all the rows in the table. So we are using the scope of the table. We can check that if we go over here to our measure and right click on it, and we can see that the compute using is the table down. Let's say that we would like to have an index for each group, not for the whole table. So let's go and switch it to the pane down. So now as you can see, the calculation gonna depend on the pane, not the whole table. So for the first group, we have the first row, the bookcases, then the second, third, fourth, and so on. Then it go and reset for the second group. So on the second group, it's gonna be this row gonna be the number 1, and the last position or the index in this group gonna be the supplies, and not the last one, the fonts. So as you can see, it always reset for each group because we have specified the scope only for the pane. And now if you go and switch it to the cell, so let's go and do that, computing using cell, you can see that each cell gonna be the first value. So the position number for each row gonna be 1. So this is how it works with the scoping in Tableau. Alright, so now let's go and switch it back to a table. So computing using table down. So as you can see, it's very simple. Let's go and try another function in Tableau. We're gonna use this time the first function. So let's create a new calculated field. We're gonna call it first, and the function gonna be as well really easy. It's gonna be first, and that's it. It's like the index. You don't have to specify anything inside the calculation. So the calculation is valid. Let's go and hit OK and check the result as well in the view. So let's drag and drop it over here. Now we can see that Tableau assigning the first row with the value of 0, and as we are moving down with the values, as you can see, the numbers are decreasing. And those numbers gonna be how many steps do we have until we reach again the top to the 0. So here, for example, we need 3 steps until we reach the first row, and as well here we have -11 until we reach the top value. So here we have like a distance between each row and the first row. And in Tableau, there is another function where it does exactly the opposite. It's going to be the last. So let's go and try it. So let's go and create a new calculated field. It's going to be the last function, not in this tutorial. So it's going to be last. And as well, it doesn't need any fields inside it. So that's all. The calculation is valid. Let's go and hit OK. And let's drag and drop it on the view over here. So now we can see that it has exactly the opposite effect of the first. So Tableau gonna go and assign the last value in our view with the 0, and as you are moving to the top, the value is gonna increase. And here again we have the distance, or how many steps do we have until we reach the last values. Okay guys, we have one more function that is very similar to the last first index, where it gonna like gives us the position number of the rows. We have the rank function. So let's go and create a new calculated field. We're gonna call it rank, and it starts with the keyword rank. And as you can see, we have 5 different functions and how to rank the data. We're going to start with the easiest one, the first one. So let's select rank. And here we can specify 2 things for Tableau. The first one can be the expression or the aggregate functions. In this view, we have the sum of sales. So let's go and define that, sum of sales. And the second information that Tableau needs it as an optional, it's going to be how to sort it, ascending or descending. If you leave it empty, Tableau going to use it as a default, the descending method. So let's stay with the defaults. That's all. The calculation is valid. Let's go and hit OK. And with that, we got a new calculated field. Let's drag and drop it to the view to check the results. So now we can see that Tableau goes and ranks all the subcategories based on the sales, sum of sales. So we can see over here that the fonts has the highest sales and we have it as a rank 1. And then the second highest sales, we have it over here as a 2 for the chairs. Alright guys, so now if you look at those 4 functions and the results, you can see that they are very similar to each other, right? They're gonna define the position number of the rows using different methods. So now you might ask, what are the use cases of those 4 functions? Well, generally there are 2 use cases. First, we can use it as a filter in the visualizations, and second, we can use it in another calculations. So for the first use case, for example, let's go and pick the rank and show it as a filters to the users. They go and specify, for example, the top 5 subcategories in the visual. And you already know that there are different methods on how to show the top product or the top subcategories in the visualizations, and this is one method on how to do that. Or we might be in a situation where we have a very big visualizations, a lot of rows, and I would like to show for the users only the first 5 rows without any specifications or ranking or anything. We can just go and show the first 5 rows. So in order to do that, we go to the first and show it as a filters. Let's go and reset the rank. So we can go over here and define, okay, I would like to see the first 5 rows. Or the opposite, we want to show the last 5 rows. So we can go to the last and show it as a filter. Let's go and reset the first. So now we can go over here and say, okay, I would like to see the last 5 rows inside my view. So this is the first use case for these very simple table calculations functions. We can use them as a filter. Alright guys, moving on to the second use case for these functions. I usually use them in another calculations to generate a reference line. Let's have a quick example. Let's go and create a new worksheet. We're going to take the order date to the columns and as well the sales to the rows. And this time we're going to have the months as well. So let's change it from year to month. And I would like to have it as a bar diagram. And as usual, I want to show the labels and as well the colors from the measure. So the task now is to show a reference line based from the first value in the diagram. So we have the first value of 21,000. So I would like to have it as a reference in order to compare the other months with it. So we can do that using the function first, but we have to add it in another calculations. Now, in order to make it simpler to see how this works, I'm just going to go and duplicate this view in order to make it like a table. So let's go to the show me over here and switch it to a table. And then I'm going to take the months to the rows. Now we have a very nice table. I would like now to have the first value as a new calculated field. Okay, and I would like as well to add to this view the values from the first function. So let's go and get the field that we already created and drop it on the view. So as you can see, the first row in this table is going to be the January 2018. So we have the value of 0, and I would like to show now the sales only for this row. I'm not interested with the other rows. Only for the first row, we have to show the sales. So in order to do that, we have to go and create a new calculated field. So let's call it first sales. And the logic can be like this. We're going to check if first function equal to 0. So if we are at the first row, as you can see, we have here the 0 value. What can happen? We want to show the sales. So it's going to be then sum. And we're going to have the field sales. Otherwise, we don't want to show the sales. So that means we can go and end the if statements. So with that, as you can see, if the position number is going to be 0, like the first one, then show the sales, otherwise don't show anything. So let's go and hit OK. And with that, as usual, we got our new measure. Let's drag and drop it to the view over here. And as you can see, Tableau can show the sales only if the first equals to 0. And if not, as you can see, we don't have anything. So with that, we got the first value in the sales, and now we can go and use it as a reference line. In order to do that, we're going to go back to our original sheet, and let's go and add our new calculated field to the details. Then let's go to the axis to the sales, right click on it and add reference line. The value going to be based on our new calculated field. So let's go and switch it to the first of sales. And we can go as well and change the label from computations to custom, and we can say, okay, this is the first. So that's it. Let's go and hit OK. Now, as you can see, we got our new reference line, and the value of this reference line gonna be based always from the first value. So as you can see, it's gonna be 21,000. So we can go now and compare the other values to our reference line, and as well, this can be very dynamic. So that means, for example, let's go and add a filter to our view. So let's go to the order date and show the filter. So now what can happen if we deselect the 2018, the first value gonna be from January 2019. So here we're gonna get the 47,000 as a reference line. So with that, we can understand the power of table calculations. They are based on the visualizations, not based on the data source. So anything you change individual, the table calculation gonna react to it, which makes it very dynamic. So this is another use case for those four functions: first, last, index, rank, and so on. For example, you can go and say, let's make the reference line based from the last value in the table, so you can go and switch it. So that's it for those four functions. Alright guys, now we're going to talk about a very important and very common table calculation in Tableau. It is the running total. The running total is going to go and sum all the values as they progress over the time. For example, in this view, we can track the performance of our business, where we can go and compare the three different categories of our products, where we can see here the development or the progress of customers and as well the orders, in order to quickly understand whether our business is growing or declining. So now if you compare in this view those three categories, you can see that the office supplies is growing very fast if you compare to the two others. So as you can see, using the running total in our view help us to understand the progress, the performance of our business. So now let's go and understand how this function works in Tableau. Okay guys, so how the running total calculation works, it's gonna go and add each value to the sum of all previous values. Let's have an example in order to understand it. We have over here the months and the sales as well, and we want to build the running sum. So we start with the first value, so we are currently at the first row, and since we don't have any previous sum of values, it's gonna be exactly the same value. So the calculation gonna be the current running total gonna equal to the sales value. So that means in the output we're gonna get exactly the same value, 2,607. Moving on to the next month, to the February. So currently we are at this level, at the sales 523, and the previous running total gonna be the old one from January. So now in order to get the running total for February, it's gonna be simply adding those two values. So we are adding the sales value plus the previous total run, and with that we will get 2,590. So as you can see, we are simply adding the current sales with the previous running value. So let's move to the next month. We have a new current, we have the 6,422, and we're gonna add it again here to the previous running total. So we have again the same formula, and with that we're gonna get 9,013. So as you can see, we are just adding the current sales with the previous running total from the previous month. So we can proceed and progress our table until we reach the last one. It's gonna be exactly the same. So we are currently at December, and this is our current value. We're gonna go and add it to the previous running total from the previous month, November, until we're gonna get the last value. And with that we have the final value for the total run. As you can see, we build like a progress or development of the sales over the months. So this is how the calculation of the running total works. Let's go back to Tableau in order to learn how to create it and build the visualization using the running total. Okay, so let's start with the big data source and let's go to the products. Here we're gonna get our category to the rows, and then we need the date. So we're gonna get the order dates from the table orders and put it on the columns. We need it as a continuous month. So right click on it, and then let's switch it to this option over here. Now we need the measures because we are tracking the progress of customers. We want the count of customers. So we're gonna go to the customers over here, and let's grab this measure, customers count, and put it in the view. And now we're gonna go and change the visual from a line to bar. So we're gonna go to the marks over here and change it to bar. So now we have here the total number of customers for each month. We still don't have the running total. In order to do that, it's very simple. We're gonna go and use the quick table calculations. It is the easiest one. So right click on the customers over here, and then let's add quick table calculations, and simply here the running total. Let's go there. So now we can see that Tableau converted to running totals for each category, and we can see immediately that the progress of customers in the office supplies is the best. So as you can see, it's very simple. What we are missing now is the count of orders, the number of orders. So let's go and get our second measure. It's going to be the orders count, and let's grab it and put it near the customers over here. But as you can see, both of the measures are very similar, so we have to change the visual for the orders in order to understand the differences between the two measures. So how to do that? If you go to the marks over here, you can see we have three sections. The first one is all. That means anything that I'm going to configure over here, it's going to affect everything, both of the measures. But now since we want to change the visual only for the orders, we're going to switch the marks to the orders. So let's click on that. In this tab now, I'm configuring the running total of the orders. So instead of bar, I would like to have it as a line. And if you go to the colors over here, we can add this dotted line in order to see like the differences between the months, and I can reduce as well the opacity in this line. All right, so now the next step, we're going to go and change the colors because both of them are blue. So let's go to all and let's grab from the left side the measure names. So let's go and put it over here on the colors. The next thing that we can do is to merge those two axes for each category into one. So I would like to have only one axis. In order to do that, let's go to the orders, right click on it, and here we have an option called dual axis. So what it's going to do, it's going to merge those two axes into one. So let's go and click on it. So now as you can see, we got only one axis for each category. We don't have anymore the split between two axes. So now we have it only in one view. So now we can see that we got only one axis for each category. We don't have anymore the split between the two measures, everything in one. So now we can see that the axes are on the left and on the right. The next step, what we usually do is, but not always, is to go and synchronize those axes. So right click on it, and we have here the option synchronize axes. So with that, both of the axes are at the same level. We can go now and hide the right one because it is useless to have the same information twice on the left and on the right. So I will go and hide the header from the right side, and maybe we can go and get rid of those informations that we have on the axis. So go and edit the axe, and we can go and remove the title. So that's it, it's close. I'm just minimizing the information that we have inside one view. So that's it. As you can see, now we can track the progress of the customers and orders by the category using the function that is very commonly used, the running total. Alright everyone, so now we're going to talk about the last table calculation function. We have the difference. The difference is very simple. It's going to find the difference between two data points. And there are many use cases for this function, but the most famous one is to compare two things. For example, to compare period to period. A very common one is to compare the sales or profit month by month or year over year in order to uncover seasonality or cyclical patterns. So now let's go and understand how this function works. Alright, so now in order to understand how the calculation works, we're going to have the following examples where we have the sales over the months. In the calculations, let's say that we are currently at the month May, so the current value going to be this value. And for Tableau, in order to create the difference, it needs always two data points. The first one always going to be the current value. So in this example, going to be the current sales of May. And the second data point, here we have more freedom where we're going to select which value going to be compared to the current value. And in Tableau, we have four different options. The first one, we can go and compare the current month with the previous month. So in this example, we can compare the May with April. So if you define it like this with the previous, Tableau going to go and simply find the differences between the current and the previous. So Tableau going to go and just subtract those two values. This is the first option. The second option that we have is to compare the current value with the next month. So in this example, we're going to compare the month of May, the current one, with the month of June. So Tableau going to go and simply find the differences between the current and the next months, and it's going to go and subtract the values. And now moving on to the third option, we can compare the current month with the first month, the first value that we have inside this table. So that means in this example, if we define for Tableau the first, that means Tableau going to go and find the differences between the current sales, it's going to be the sales of May, with the first. So we have it as January. And then go and subtract the values. So now moving on to the last one, I think you already got it. We're going to compare the current month, the May, with the last month, the month of December. So Tableau going to go and find the differences between the current value of May with the last value inside the visualizations of December. So it's going to go and subtract the two values. So as you can see, we have here 4 different options on which value we are comparing with the current. So either the previous value, the next value, the first value, or the last value. So that means in Tableau we get like really great control which data points can be compared to each others. So now let's go back to Tableau in order to start practicing for this function. Alright everyone, so now we're gonna go and create a view in order to compare the sales over the time, over the years. So we're gonna go with the big data source. Let's go to the orders and get the order date to the columns to have the years. Then we would like to have in the rows the months and the quarter. So hold Control and just duplicate it like twice. The first one gonna be the quarter, so let's change the format to quarter. And the second one gonna be for the month. So we're gonna replace it as well to the month. Now I would like to make the table a little bit bigger. So I'm just gonna stretch it from the rows and as well from the columns. And now what is missing, of course, our measure. Let's go and get the sales and put it in the view. So now we have the sales aggregated by the months and spreaded by the years. So now we have to create the differences between those years. In order to do that, we're going to go to our measure, right click on it, and this time we're going to go use this option to have more control on the calculation. So add table calculation. Let's do that. And now we have to configure a few stuff. First, we have to choose the calculation type. It's going to be the difference from. So as a default, this is correct. And as well, computing use, which scope, which direction we want. So we want the direction from left to right. We want to compare the years, which is currently correct. We don't want to compare the months together. If you want to compare that, we can switch it to table down. So with that, we are now comparing the months together, but now we want to compare the years. In order to do that, let's select the table across, and then we have to specify for Tableau relative to, and here we have to define one of the 4 options that we learned before. So we have the previous, next, first, and last. And now in this example, we want to compare the current year with the previous year. So we're gonna stay with the previous. So that means, for example, let's pick this value over here. It's gonna be the differences between the sales of 2022 January and the year before with the same month. So it's gonna be the difference between this year and the year of 2021 January. And that's why for the whole year of 2018 we don't have any values, because in this view we don't have 2017, we don't have a previous year. It's gonna be the first year. That's why it's completely empty. Alright, so with that we have created the table calculations, but as usual we're gonna go and change the view that we are currently presenting for the users. So what I would do now, I would reduce the number of years to only 2 years. So let's go and apply a filter. So show filters, and I would pick the last 2 years. And now I would like to add to the view the total sales for each month. So in order to do that, let's go and grab the sales and drop it to the view. So now on the left side, we have the differences in sales, and then we have the aggregate of sales. So now we can see very easily where those numbers come from. It is the differences between those 2 years. All right, so the next step, let's go and replace those numbers with visuals, with bars. So in order to do that, we're going to take our measures and put it on the columns. So this is the first and the second, and then let's change the visual instead of line to bar. So let's go to the marks over here and say we would like to have the bars. All right, so here, as you can see, all the measures having the same coloring. So instead of that, I would like to change the coloring of the differences. So let's go to the sum of sales over here. As you can see, we have the icon of table calculations, and then let's drag and drop the sum of sales, the table calculations, to the color by holding Control. And let's change the colors of the first measure. So let's switch the sum of sales, the aggregations, and go to the colors, and let's pick any color from here, like for example the blue. So that's it. Those informations comes from the total sales, from the aggregate calculations, and this one comes from the table calculations, and it's very simple to create. And with that, we can go and compare the years for the sales. And now if you would like to analyze the differences between those 2 years, you can see in January, for example, there is no big difference between the year 2021 and 2022. There is like small growth. But if you go, for example, to February, you can see there are big differences between the 2 years. We have made a lot of sales in this month. And another thing to notice here is that in November, we made less sales than the year before. So as you can see, we can very quickly find the differences between those sales in 2022 and the sales of the year before. So this is the power of the difference function. It's gonna help us to compare two things, like the years or maybe the categories, month, and so on. Alright, so that's all for the difference function in Tableau. Alright everyone, so that's all. We have covered the 4 types of Tableau calculations, and with that you have learned around 60 different functions in Tableau, so that you have enough tools in order to create new fields in your data source and as well to manipulate your data. And with that we have completed the section Tableau calculations. And now in the next section things gonna get really interesting, where we're gonna go and build around 63 Tableau charts. We're gonna start with the basic charts like bar charts, and we're gonna progress to more complex charts in Tableau. Now, before we start learning how to build charts in Tableau, we have to understand some basics, like for example, how to add multiple measures in one single view. I saw many new Tableau developers that they get confused on how to add a second measure to the visualization, because in Tableau we have different places and different methods on how to add multiple measures in one single view. And here in Tableau we have 3 methods. The first one is to use individual axes for each measure. The second method is to use one single shared axis using measure values and measure names, and the third one is to use dual axes in Tableau. So now we're gonna go and learn those methods step by step, and we're gonna learn as well the advantages and disadvantages of each method. So let's go. Alright guys, now we're gonna start with the first method. We have the individual axes for each measure. So let's see how we can create it and how it's gonna look like. Let's go for example to our big data source. Let's pick the order date to the columns, and now in order to create individual axes for each measure, we're gonna drag and drop the measures in the rows or in the columns. So for example, we're gonna take the sales and put it in the rows, and let's take as well the profits and drag and drop it to the rows as well. And now we can see in our view that each measure has its own axis, so that's why we call it individual axis for each measure. So we can see for the sales we have this axis that starts from 0 to 1 million, and for the profit it starts from 0 to 100k. And those two axes for those two measures are completely separated from each other's. There is no overlapping or anything. And now of course we have 2 measures. We can go and add a third, fourth, and so on. So there is no limitations on how many measures we can add to our visualizations. So we can see now we have 4 measures, and you can see each of those measures has different axes with different ranges. And now I would like to understand something very important in Tableau, that once you are adding multiple measures to the views, you will get multiple pages on the marks. The marks in Tableau is the place where you're gonna go and customize the visualizations, to customize the charts that we have over here in our view. And since we have multiple measures, we will get multiple pages in the marks. So let's check what do we have over here. So we have the first one is all. Then we have an individual mark for each measure that we have inside our view. So now let's understand how this works. Let's start with the first one, the all. Now in this page, anything that you change in the setup, it's going to be reflected for all measures for all charts. For example, instead of having the line, I would like to have the bar. But now if I change it to bar, as you can see, all the measures going to be changed to bar charts. Or if you go over here, for example, to the colors and change it to black, you can see that all our measures now are black, and so on. If you go to the size, reduce the size, you can see the size of all our measures going to be reduced. So anything that I'm changing in the all, it's going to be reflected for all measures in the view. But now since we have individual axes for each measures, we can go and customize each of those charts individually. So for example, let's say that I would like to change only the sales. I can go to the marks of sales over here. So let's switch to the page of sum of sales, and then instead of having bar, I would like to have it as a line. So now we can see we have changed the chart type only for the sales. Everything else can stay as a bar chart. And the same thing for the profit. You can go over here to the profits and say, okay, instead of black, I would like to have it, for example, as blue. So as you can see, this customization is going to be done only for this measure, only for the profits. And then the same thing for the other measures. If you say, okay, for the quantity, I would like to change the chart type. Instead of bar, let's go for something like area. So let's switch to the quantity, and then let's go to the area over here. So with that, we have changed only the chart type for the quantity. So you can see those marks are really helpful in order to customize our charts, and you can go and do that individually for each measure, or you can go to all measures over here and then do the changes for all measures together. So that's all for the marks. They are really important in order to customize the charts inside our visualizations. One more thing that's important to understand is that we have here 4 tabs inside the marks because we have 4 measures. Well, because we have continuous continuous measures. So for example, for the years, we don't have here any tab in order to customize the years because it is discrete. For example, let's go and switch the sum of sales from continuous measures to discrete. So right click on it and go to discrete. So with that, you can see that the sum of sales did disappear from the mark. So that means we cannot customize it anymore because it is discrete. So let's go and change it again back to continuous. And with that, we're gonna get it again in the marks. So you can customize only continuous fields. All right, guys. So now as you can see for this method, we can go and customize our charts individually and as we want. And another advantage is that we can go and add as many measures as we want inside our visualizations. But the disadvantage here is that we have separated axes, which is in some situations, it's really hard to compare the measures together if they are like splitted like this. That's why we have in Tableau different methods in order to combine and to merge the axes and the charts together. So that's all for the first method, where we're gonna have individual axes for each measure. Alright guys, moving on to another method in order to combine multiple measures in one view, and that is by sharing the same axis. We can do that using the measure names and measure values. If you check the data pane in each data source in Tableau, you will find always two fields. We will have always measure names and measure values. Those two fields, the measure names and values, they are automatically generated from Tableau. They don't come from the original source of your data. So what are those fields? The measure names is a discrete dimension that contains the names of all measures that you have inside your data source. And in the other hand, we have the measure values. It is continuous measure that contains the values of all measures that you have inside your data source. And in Tableau, there are two ways in order to use the measure names and values. The first one is by simply just drag and drop from the data pane to the view. So let's take, for example, the measure names to the rows. And as you can see, currently no measure values are selected because we don't have anything in the view. So now what we're gonna do, we're gonna go to the measure values and let's drag and drop it to the text over here. And now you can see in the view all our measures that we have inside our data source. So the count of customers, count of orders, discounts, profit, sales, and so on. So those are all available measures that Tableau can find inside your data source. So here again, the measure name gonna be the name of the measure. So the count of customers, count of orders, those informations comes from the measure names, and the values of those measures gonna come from the measure values. So as you can see, it's very simple. The names of the measures, the count of customers, discount, and profit, those names comes from the measure names, and the values that we have inside this view comes from the measure values. So here you can control stuff. For example, you can go and remove any measure that you don't want to see inside our view. So for example, let's go and remove the sum of unit price. So just drag and drop it somewhere outside. And as you can see, Tableau created immediately a filter. So if you go over here on the filters and edit it, you will see a list of all measures that we have inside our data source. And as well, if you want to remove some measures, you can go and deactivate or deselect the measures that you don't want to see inside our view. Let's go and hit OK, and with that we have reduced the number of measures inside the view to 4. And one more thing that we can do over here, that we can go and change the sort of the measures inside our view. So for example, let's take the count of customers from the top and put it in the bottom. So as you can see, we just changed the order of the measures inside the view. Alright, so this is one way in order to use the measure names and measure values inside the visualizations, by just drag and drop them inside the view. But there is like another quick way in order to use those informations. Let me show you what I mean. I'm just gonna go and remove everything from our view and then start from scratch. Let's take the order date to the columns, and let's take, for example, the sales to the rows. So far we have only one measure in our view, everything as normal. But now let's say that I would like to add another measure to the view. Before we learn that, we take the profit and put it near the sales. But with that, we have learned that Tableau gonna go and create two individual axes. We don't want that, so let me just remove it. I would like to have one axis for both of the measures. So in order to do that, we can use the measure values and names. And in order to quickly generate that, let's take the profits, and now very slowly let's just drag it to the axis of the sales. And as you can see, now Tableau gonna show us two green vertical lines. So with that, we are telling Tableau that I would like to share the same axis for two different measures. So let's just drop it on the axis, and here Tableau gonna go and convert everything. So we don't have anymore here the sum of sales, we have now the measure values, and in the filters we have the measure names. Inside it we will get only two measures and the sales. So as you can see, Tableau can prepare everything for us, and this is a quick way in order to use multiple measures using the measure values and measure names. And we can see as well here in the measure values that we have only those two measures. So now let's check the visual. As you can see, we have only one axis for two measures. So the green one gonna be the sales and the gray one gonna be the profits. So that means those two measures are sharing the same axis. And of course we can go and add more measures to our view, not only two. We can take, for example, the discounts. We can go and drop it inside the measure values to the last one, for example, and with that we got 3 lines. 3 measures are sharing the same axis. So it's really nice and compact way in order to compare multiple measures using the same axis. But of course here you have to pay attention to the scale of the axis. For example, the scale of the sales, as you can see, the green one is really huge, from 0 to 1 million. Now if you check the discount, as you can see, everything like almost 0 because the scale compared to the sales is very small. That's why for this method it makes sense to use multiple measures in the same axis if they have a similar scale of data. But if there is like big difference in the scales, the visual will not make sense in order to compare two measures. So in this example, it doesn't really make sense to use the discount inside these visualizations because we cannot really compare it. It has really small scale. One more disadvantage of this method is that if you check the marks over here, you can see that we have only one tab for everything. We don't have individual marks for each measure, and that means we cannot go and customize each measure as we want, like we saw before in the method 1, where we want to use in one case, for example, the line diagram, and another measure we can use the bar diagram and so on. So we cannot go and customize individually each measure, but instead all those measures are sharing the same setup for the visualizations. So that means let's go, for example, and go and change the size. If we do that, it's gonna affect all measures inside the view, and I cannot change it individually. So everything that you are making here or changing in the visual, it can affect all the measures. For example, let's go and change it to bar diagram and so on. The only thing that you can go and customize is the colors. So if you go to the colors over here and edit colors, you can assign for each measure a different value, but that's all. So we cannot go and customize the charts as we want. So if you use measure values and measure names, pay attention, you don't have the freedom of changing the visuals of your charts. But it's still very useful in many cases where you want to have multiple measures sharing the same single axis. Alright, so with that I hope it's more clear now why do we have in Tableau measure values and measure names. Alright everyone, so now moving on to the last method. In order to combine multiple measures in one view, we can use the dual axis. Dual axes are a really great way and very useful in many scenarios where you can go and compare two measures together. So let's see how this works in Tableau, and there are two ways on how to create dual axis in Tableau. The first one I'm going to show you now is that let's take, for example, the order date to the columns, and then let's take the sales informations to the rows. And now I would like to get another measure inside our view. So let's take the profit and just put it in the rows side by side near the sales. So here we are back to the method 1, where we have two measures separated with two individual axes. So now as you can see, those two measures are separated from each other's. I would like to bring those two visuals on top of each other's. So how to do it? Let's go back to our measure. So as you can see, we have two measures, the sales and the profits. We're gonna go to the profit, to the one on the right side, right click on it, and here we have the option of dual axis. So let's go and click on that. So now as you can see, those two charts now are on top of each other's using dual axis. The axis for the sales and the axis of the profits side by side. And we can see as well the shape of those measures that change. So now instead of having two green pills, we have now one green pill from two measures, the sales and the profits. And now if you check the scales of those dual axes, you can see that the sales as usual from 0 to 1 million and the profits from 0 to 100k. So now here you have two options. Either you can leave it as it is with two different scales, or you can go and make them similar to each other's. And this is what we do in most situations. We go and synchronize those two axes. So in order to do that, let's go to the profit over here on this axis, right click on it, and here we have the option of synchronize axis. So let's go and select that. As you can see now, the profit scale has exactly the same scale as the sales. It starts from 0 to 1 million, and the marked or the visual did adjust as well to the new scale. So as you can see now, we have it on the bottom, before we had it near the sales. And now you might ask, you know what, why do we use dual axis? I can just go and use the measure values like the method 2, and I can add as many measures as I want to the view. So why do we have dual axis? Well, there is two reasons for that. First, here you have the option to decide whether you want to synchronize the axis or not. So if you go to the method 1 with the measure values, you can see that everything is synchronized and you have have only one axis and we cannot change that. But if we go back to the dual axis, we have always the option to synchronize the axis or not. So this is one benefit. The major benefit of dual axis is that I can go now and customize each measure as I want. So if you check the marks, we have here again a tab for each measure. So again, they're all gonna customize both of the measures. But if we go to the sum of sales, we can go and decide the visual setup of this measure. So for example, I can go over here and change the size, or I can go to the sum of profits and say, instead of the line diagram, I would like to get a bar diagram. So here is exactly the advantage of the dual axis, where we can go and customize the chart or the measures individually, but still using the same axis. And you don't have this option if you are using the measure values, because you have to make a decision or a setup for all measures. But the disadvantage here is that it is dual axis, so only two measures. But it's still a great way in order to compare two measures in Tableau. I would like to show you now the second method on how to create quickly dual axis in Tableau. So let's go and remove those stuff. And then let's take again the sales. And now for the second measure, instead of dragging and dropping it here near the sales and then switch it to dual, what we're going to do, we're going to go to the visual over here. And if you move it to the right side, you can see that we have one vertical line. And here, be careful. If you move it to the axis, you have two vertical lines where you're going to have the measure values and measure names. We don't want that. We want the dual axis. So just move it to the right side, the opposite side of the axis. And you can see we have one vertical green line. If you drop it, Tableau gonna go and create immediately a dual axis between those two measures. So this is how you can create dual axis in Tableau quickly. And one last point about the dual axis is to understand the order of the measures has an effect on the visual. So let me show you what I mean. I'm gonna go now to the profit and change it from bar diagram to line diagram. And as you can see, the red line from the profit is like in front of the sales. So that means the measure sales is in the back and the profit is in the front. If you want to switch that in the visual, what you're gonna do, you're just gonna switch the order of the dual axis. So if we take the sales from left and just put it on the right, and as you can see now, the bar diagram in the front and the line diagram in the background, which in this situation, it's not really cool to have the line behind the bars. So now let's go and switch it again. So the profit on the right side. So with that, we're gonna get it in the front and the sales in the back. All right, so that's all for the dual axis. And now, of course, in Tableau, you can go and mix all those methods together in single view. So here we have a dual axis in this example. I can go now and add the measure values instead of the profit. So instead of having the profit, we can have the measure values, the method 2. So in order to do that, let's take, for example, the quantity, and let's drag and drop it on the axis of the profit. So let's drop it over here, and as you can see, Tableau immediately switch the sum of profit to measure values. But still on the left side, we have sales. So now we are doing a dual axis between the sales and a bunch of measures. So now we can go and add more measures to the measure values. So let's take the unit price and add it over here. We can add a discount, but now let's just change the colors in order to make it more clear. So now I am at the tab of the measure values. Click on the colors, edit colors, and now the quantity, I'm gonna give it green. Yeah, unit price, let's give it gray, discounts, this color, and that's all. So with that, as you can see, we have different lines, but all of them are lines. We cannot change that because it is a measure value. So all of them are sharing the same setup. And on the background, we have the sum of sales from the dual axis. So that means you can go and combine those stuff. And of course, we can go and add the method 1. So let's take the count of the orders and just drag and drop it to the rows over here. So with that, you can see that Tableau did go and create an individual axis for the count of orders. So that means if we look now to our measures in this view, the first one, the sum of sales, we are using the dual axis, this bar diagram, the blue one. And then on the right side of the dual axis, we have bunch or bundle of measures. So here we have the sum of profit, quantity, unit price, and discount. So we have a group of measures as a part of the dual axis using the measure values. Count of order, it is completely separated and not sharing the axis with the others. So we have it as an individual axis using the method 1. All right, so as you can see, you can mix stuff, and this is exactly the power of Tableau, where we have high customizations on how to visual our data. Alright everyone, so now let's have a quick summarize. In order to combine multiple measures in single view in single visualizations in Tableau, we have three methods. The first one is to use individual axes. That means we're gonna have for each measure a different separated independent axis. And the main advantage of this method is that we can go for each measure and decide about the visuals, which visual type we're gonna use, the colors, the sizing, and so on. So the customizing of the measures is going to be independently. And the second benefit is that we can go and add as many measures as we want inside one view. But the weak point in this method is that it's really hard to compare those measures together. That's why we have the second method where we can go and compare all those measures together using one shared or single axis. And we can create such a visualizations using the measure names and the measure values. So we have only one axis and we can have multiple measures sharing the same axis. Well, the main benefit over here is that we can add as many measures as we want, and as well we can compare those measures better than the method one since they share the same axis. But the disadvantage in this method is that we cannot go and customize each of those measures independently. So that means all those measures are gonna share the same configurations of the visualization. So we cannot use here a line, then a bar, then change something else. We have always to use the same visualizations for all measures. And that's why we have the third method in Tableau to use the dual axis. So the main benefit of the dual axis is that we can compare two measures closely to each other's. We can define whether we're gonna synchronize the axis or not. And here the advantage compared to the previous one, the single axis, is that we can customize the visuals for each measures independently. So here we have a line diagram together with a bar diagram. Only disadvantage of this method is that we can compare only two measures. Alright guys, so that was the different methods on how to add multiple measures in one single view and when to use them. Next we're gonna start building basic charts, and first we're gonna have the bar charts. Now we have a marathon where we're gonna go and build 60 different charts in Tableau. So we will start with very basic charts and we're gonna end up making very complex charts. And we will have different charts like bar charts, line charts, area, maps, circles, and everything. But here I have to warn you, if you just sit down and watch the video, it will not help you. So here my recommendation is that you pause the video, you make the same charts, and then you continue. So you don't jump to the next chart without practicing with me. So let's stop talking and wasting time. Let's go and start building charts in Tableau. Alright, so now we're gonna start with the easy stuff where we're gonna build a bar chart in rows. So let's start with the big data source and let's take the subcategory to the rows, and then we need a measure. Let's take the sales and put it in the columns. And now with that we got the sales by category, and now in order to make it bigger I'm just gonna go over here. Instead of standards, let's take the entire view. And now as you can see we have bars in the rows. Tableau can use bar chart as a default, but in case you have something else you can go to the marks over here. Instead of automatic you can move it to bar. So let's go and click on that. Nothing gonna change because currently is a bar chart, and we usually use the bar charts and rows in order to make ranking. So in order to do that, let's go to the sales and sort our data. So with that we got a very nice ranking in our charts. One more thing that I usually add is the coloring. So I take the measure, the sum of sales, hold control and put it on the colors. Alright, so that's all for the bar charts and rows. Okay, the next one we have the bar charts in columns. It's very easy and very similar to the rows. I just duplicated the worksheets. So now here instead of having the dimension on the rows, we have to move it to the columns. So we have to switch between the measure and the dimension. In order to do that, it's very simple. Let's go to the quick menu over here and just switch it. So with that we got the bars now on the columns. So as you can see it's very simple. We usually use this as well for ranking. And of course now the question is when to use columns and when to use rows. If you have a dimensions with low cardinality, like here we have the subcategory, you can go and use the columns. But if your dimension has a high cardinality, a lot of values, you can go and use the rows in order to have like a long list and you can scroll down. It's always better to scroll down than to scroll to the right sides. So if you have a lot of values inside your dimension, go with the bar rows. But if you have low number of values inside your dimension, go with the column bars. Alright, moving on to another bar chart, we have the side-by-side bars. In the previous bar charts, we have used only one dimension. This time we're gonna go and use two dimensions. So let's go and build it. First, I would like to get the dimension country. to the columns, and then let's go and get our measure, the sales, to the rows. So with that we got the normal bar charts. But now if you go and add another dimension to the columns, you will get side-by-side bar charts. And the second dimension gonna be the years of order dates. So drag and drop the order dates to the columns. So as you can see, Tableau did convert it to line charts. We don't want that, we want bar charts. That's why we go to the marks over here, and instead of automatic, we're gonna switch it to bars. And again here I would like to make it entire view. Now we have a lot of data inside the view, so we have 5 years of data. I would like to have only 2 values, so I would like to compare the last 2 years. So let's drag the years to the filters, and then here I'm gonna filter using the years. So select the years, next, and let's have only the last 2 years. Click OK. And the last thing that I would like to add is the coloring. Since we have 2 years, I would like to have for each year a color. So let's take the years, hold Control, and put it on the colors, and that's it. We have now really nice separations between the values. So now as you can see, we got side-by-side bars, and it's really useful in order to compare multiple values in each category. So with that we can really easily compare the last 2 years in each country. And here in this type of charts, try to not have a lot of data, then it's gonna be really hard to compare data. So as you can see, we just have a filter on the data in order to compare only the last 2 years. So that's it for the side-by-side charts. Alright, moving on to the next one, we have the bar chart over time. It's a very famous one. You're gonna find it almost in each dashboard. So let's see how we're gonna build it. We're gonna go to the order dates. Let's put it on the columns. And as usual, we're gonna have the years. Let's go and get our measure, the sales, and put it in the rows. And here as a default, Tableau gonna show it as a line. So let's go and switch it to the bars since we are working on the bar charts. So with that, we got very nicely the sales over the years, but we usually add more details because those data are very aggregated. So let's go and add another date dimension. In order to do that, let's just drill down the years. So click on this plus sign, and with that we got the second dimension, the quarter, and here we can see more details about how the sales are changing over the time. So the main use case of this bar chart is to show how the data are changing over time, to show trends. So if you have such a requirement, go with the bar chart over time. Okay, moving on to the next one, we have the stacked bar chart. The requirement for this one is going to be similar to the side-by-side. We're going to use 2 different dimensions. So now let's go and build it. I would like to see the total sales of each month for this year. So in order to do that, let's take the order date to the columns, and let's take the sales to the rows. And now I'm gonna go and switch the years to months. So right click on it and let's select this format, the month, so that we got those bars that represent the total sales for each month in this year. But now I would like to add more information to this view in order to compare as well the categories. So now let's go and get the categories, but here is always the question where we're gonna place it. If you put it in the columns, what you're gonna get, you will get side-by-side bars. We don't want that, we want to get stacked charts. In order to do that, let's take the category and put it just on the colors. So let's go and do that, and with that we got this information, this dimension as a color inside each bar, and with that we're gonna have the stacked bar chart. So now as you can see, the main purpose of the stacked bar chart is first to have the total of sales over the time, so we can compare the months and how the sales are developing over the time. Then the second task, which is not the main task, is to go and compare the categories to see how the categories are contributing in the total sales of each month. So that's all for the stacked bar chart. Alright, now we have a very similar chart to the previous one. We have the full stacked bar chart, or sometimes we call it 100% stacked bar chart. So now I just duplicated the previous one, and as you can see in the normal stacked bar charts, each bar starts and ends differently from month to month. Total sales is not really important in these charts. What is important is now to compare the subcategories over the time. And a very nice way in order to do that is to have full stacked bar. That means each bars in our visualizations can has exactly the same length, and it starts from 0% to 100%. So in order to do that, let's go to the sum of sales, right click on it, and then let's go to the quick table calculations and have the percent of total. So with that we got the percent of total instead of the total sales as a value, but we're still not there because those bars are not having the same length. In order to do that, let's go back to the sum of sales, right click on it, and let's go to edit table calculations. So let's go inside. And now what we're gonna do over here, instead of having table across, we're gonna have specific dimension. So let's go and switch on that, and we're gonna select only the category since we are focusing only in the category. So let's remove month of the order date. And now as you can see, we get immediately a full stacks. So let's go and close this. So now as you can see, all those bars has exactly the same length, and they all start with the 0% and end up with the 100%. And we call this type of chart as part to whole. That means I would like to see and understand how each category are relate to the whole sales of each month. So now let's quickly summarize when to use which chart. If you want to focus on comparing the categories over the times, then go with the full 100% stacked bar charts. But if it's more important to show the total sales of each month, then compare the categories, then go with the normal stacked bar charts. Alright, moving on to the last type of bars, we have the small multiple bar charts. Many bar charts inside our visualizations, and we can do that by adding more than 2 dimensions. So let's start with the first dimension. We're gonna go to the countries from the data pane. Let's put it in the columns. And with that, we got the values of the countries as columns. I would like now to add rows from the category. So let's get the second dimension, the categories, to the rows. And now I would like to fill those informations in order to see some data. So let's go and get our measures, the sales. Drag and drop it to the rows over here. So now as you can see, our bars are not really small, so still we have big bars inside our view, and always we can go and check how many marks or how many bars do we have inside our view. By checking this information over here, we can see that we have 12 marks. So now let's go and get our third dimension. It's gonna be the order dates. So let's get the order date to the columns, and now we went from 12 to 60 marks or 60 data points. Now Tableau switch it to lines. I would like to bring it back to bars. So let's go to the marks, switch it to bars, but still our bars are not really mini or small. So in order to go more in details inside our view, instead of using the years, we're gonna go with the month. So let's go and change the format, right click on it, and let's choose this format, the continuous one, the month. So now if you check again, we went from 60 to 707 marks. Many bars inside our view. I would like to add as well some colorings to it. Let's go and get the country to the colors. So that's it. With that, we got small multiple bar charts. As you can see, as you are adding more dimensions to the view, you are splitting the measure to more and more details. Okay, next we have the bar in bar chart. Previously we have compared 2 dimensions inside our view, but now how about to compare 2 measures in our views using bars? So let's see how we can do that. As usual, we're gonna take our subcategory to the rows, and then let's take the first measure. It's gonna be the sales to the columns. So now with that, we got our standard bar charts. Let's go and sort it by the sales. Now we need our second measure. So let's go and take the quantity and put it as well in the columns. So now with that, we got individual axes for each measures, and we can go and compare the data. But it's way more better if you have 2 measures and you want to compare them, is to use the dual axis as we learned before in the previous tutorial. So let's go and use the dual axis. We're gonna go to the quantity, right click on it, and let's go to the dual axis. Now here Tableau did decide to go with other visualizations since we have automatic. Instead of that, I would like to switch it back to bars, and as you know, in the dual axis we will get different tabs inside our marks. So now since both of them gonna be bars, we're gonna go to all and then select, instead of automatic, we're gonna have the bars. But now as you can see, we are not there yet. It's like the stacked bar, but actually it's not stacked. So in order to change that, what we're gonna do, we're gonna go for each individual measure and change the setup. But first I would like to change the coloring. I don't like those current informations. So let's go to the quantity, make it orange. The sales gonna be blue. That's it, okay? So now what we're gonna do in order to have bar in bar, we're gonna go and change the size of the quantity. So let's go to quantity over here, go to the size, and just make it a little bit smaller. So now we can see in the background the big blue bar, and in the front we have this small orange bar. So with that we got something like bar in bar chart, which is really great in order to compare two measures using dual axis. So here, for example, if you check the category art, you can see that the quantity is really huge, but we are generating very few sales compared, for example, to the copiers. We have less quantity that is ordered, but we have huge sales. So it's really nice way in order to compare measures. Alright, the next one is going to be a fun one where we're going to create barcode charts. We usually use it in order to show more details inside each bar. So let's see how we can do that. As usual, we're going to get the same informations, subcategories to the rows and sales to the columns. I think you already got it. Let's go and sort it. And now what I would like to bring is a dimension with high cardinality, like the product name. So let's go and bring it, for example, to the rows over here. As you can see, Tableau is warning us and telling us there is a lot of members inside the product name. And now if you go and say, okay, add all members, what's gonna happen? The view gonna be broken and it's not really informative. But instead of that, we can take the product name and put it on the details. So let's go and do that. And now with that, we have built something like barcodes where we have the product informations inside each bars, which is sometimes useful to show all those details in one view. So that's how you build barcode charts. Alright, so now we're gonna start talking about the line charts in Tableau. They are very basics and very standards in order to show the change over time. So now let's go and build very simple line chart in Tableau. Since we are saying change over time, that means we need a date. Let's go and get the order dates to the columns, and in the rows we need our measure, sum of sales. So now as a default, as usual, Tableau gonna show the years, but instead of that, in order to make it more interesting, we're gonna go and switch it to months. So let's go and change the format to month continuous. So click on that. And now with that, we got our line charts. And if for some reason at your end, you are not getting line charts, in order to switch it to line charts, we go to the marks, and then instead of automatic, let's go and choose the line. So once you do that, you will get exactly like by me, a line chart. So this is the most basic line chart in Tableau that shows the changes over time. Okay, so next I would like to show you the different visuals that we can add to our line. So for that, let's get more measures to our view. So currently we have the sum of sales. Let's get everything like the discount, the profits, and we have already the sales. Let's take the unit price and as well the orders. So now, as you know, since we have 5 measures in our view, we get as well 5 tabs in the marks in order to individually set up the visual. So for the sum of sales, we're going to leave it as it is, as a standard line chart. But for the next one, what I'm going to do, we're going to change the path or the visual of the line. So if you go over here on the path and click on it, we will get different types of lines. So the first one going to be the standard one, the linear, but the second one going to be a step. So let's go and select that. So now if you check the discount over here, we don't have a linear charts like the sales. We have now like steps, like it's jump up and then we have steps down. Alright, so let's move next to the profit over here. So let's switch the tab to the profit. So now we're gonna go again to the path, and here we have 2 sections, the line type and the line pattern. So in the line pattern, we have the solid line, or we can make a dashed line. So let's go and select the dashed line, and as you can see now in the visuals, we have very nicely a dashed line in Tableau. So this is one more way in order to present the lines in Tableau. Let's move to the next one. To the next measure, we have the unit price. Let's switch there. And now what we can do over here, for each data point that we have in the chart, we can make a marker or like small circle. So in order to add the markers, what we're gonna do, we're gonna go to the colors over here, and then here we have the effects. So the first one is automatic, the second one to have marks, and the last one to have no marks. So let's go and switch everything to marks. And now with that, you can see the line chart in the unit price has like small circles, small data points. So this is one more visual effect on the lines in Tableau. Let's move to the last one, the count of the orders. So let's switch there. Now what we can do, we can change the size of the lines depends on the values. So in order to do that, let's take the count of orders. So with control, drag and drop it and put it on the size. So now if you take the last line, we're gonna see a really nice effect. If the values are small, we will have a thin line, but if the values are high, we will get like a heavy line. which is really looks nice. Alright guys, so as you can see, Tableau is very rich in the visualizations, and with few clicks we can change the visual representations of the lines. Alright, now we're gonna build the multiple line chart in Tableau. I'm always duplicating the sheets in order not to build everything from scratch each time. So now previously in the standard line, we can see the changes over time, but sometimes we want to add more informations. We want to compare the values of one dimensions inside this view, and we can do that by having multiple lines. So let's say that I would like to compare the values inside the category. So let's go to the categories in our products, and now let's put it on the colors. So drag and drop it to the colors, and as you can see, by doing that, Tableau gonna go and plot 3 lines for each value inside this dimension. So with that, we got multiple lines inside one view, and now we can see that it's not really informative because we have a lot of lines and a lot of zigzags. In order to reduce that, we're gonna switch the format to, let's say for example, a quarter. So now it's a little bit more clean in order to see how the data are changing over time, and you can compare the values of one dimensions. So the number of lines really depend on the values inside this dimension. One more thing about how to create those 3 lines, you don't have to have it always on the colors. If you move the category from the colors and put it on details, you're gonna get the same effect where Tableau gonna go and create multiple lines for each value, but this time without colors. So this is another method on how to create different lines in Tableau, but I think it makes more sense to have it on the colors, to have separate color for each line. So this is how you can create multiple lines in Tableau using dimension. Alright, the next one we're gonna have dual line charts. This time we're gonna go and compare 2 different measures in one view. So we're gonna create for each measure 1 line. So now I'm gonna stick with the same view where we have the sum of sales and the quarter for the order dates. So now we'd like to compare in this view 2 measures, the sum of sales and the profit. So let's take the profit and put it side by side by the sales, and with that we got 2 different lines for each measures, but I would like to have it on top of each others. So in order to do that, we're gonna go and use the dual axis. So let's go to the profit, right click on it, and here we have the option of dual axis. So with that, as you can see, it's very simple. We got a dual line charts, and here you can add more stuff. For example, you can go and synchronize those 2 axes by going to the profit, right click on it, and here we can go and synchronize it. Or of course we can go and set up each line differently. So let's go to the profit over here, go to the path, and let's make it a dashed line. So as we learned previously, using the dual axis, we got the freedom of changing the visual of each measures individually, and this is a really great way in order to compare 2 measures. Okay, moving on to the next one, we have the cumulative line charts. So currently in the standard line charts, we are using the month and the sum of sales, and we can see the total sales for each month. But sometimes we would like to understand how the things are developing or growing with the time. So now if we want to see the growth over time, we have to use a cumulative line chart. In order to do that, we're going to go to the sum of sales, and instead of having sum of sales as aggregate functions, we're going to go and create quick table calculations to have the running total. So let's go and switch that, and as you can see, we're gonna get very nicely cumulative line charts where you can see how the things are growing over the time. But of course, to make things more interesting, we're gonna add more information to our view. So let's go and get the category and generate different lines. So we're gonna drop it on the colors, and now we can see how the different categories are growing over the time. And what we can add as well to the cumulative line is the ending point of each line. So in order to do that, we're gonna go to the marks, to the labels. So click on the labels, show mark labels. But now as you can see, we have for each month 1 label. We don't want that. We want only the ending of each line. So in order to do that, we're gonna switch it from all to line end. So now if you check our lines, you can see at the start and at the end we have these informations, but the starting point is not really interesting, so we can go and disable it. So label start of line, let's go and disable it. And with that, we're gonna have the total sales of each category at the end of the line. So with that, we can go and analyze the growth over time for each category. Okay, so now we're gonna go and create small multiple line charts as we done for the bar charts. We're gonna do it now for the lines. So now what we're gonna do, we're gonna bring like at least 3 dimensions to the view in order to break down the sales to smaller lines. So let's go and do that. We're gonna get, as usual, the order date to our view. Let's get the sum of sales to the rows, and then we're gonna get another dimension, the category, to the rows as well. So as you can see now, as we are adding more dimensions, we are splitting the lines. Let's go and get the countries and put it as well to the columns. So now with that we got more charts, but Tableau gonna show it as bars since we have it as automatic. So let's go and switch it to lines. And now we have it as a discrete line. Instead of that, let's get a continuous line. In order to do that, let's go to the dates and switch it to something like the month as continuous. So let's change the format. And with that, as you can see, we get very interesting multiple line charts. And I would like to add the colors as well. So let's go and get the country, for example, and add it to the colors. And now just to enhance the visual, let's go and remove the grid. So right click over here and then let's go to formats. Then we're gonna go over here to the lines and then we have the row tab. So let's go to the grid lines and move to none. So with that, we have removed those grid lines, which is really annoying to have a lot of them. And then the last thing that we can do is that we can have the total sales of the last point. In order to do that, let's get the sum of sales, hold Control and put it to the labels. And then we're gonna go to the labels over here and let's select min max. We're gonna have it by the order date. So let's switch from automatic to month and let's have only the maximum value. So let's remove the minimum value. So with that, we got for each chart like the total sales for the last month. So with that, we have created very nice small multiple line charts in Tableau. Alright, moving on to the next one, we have the highlighted line charts in Tableau. This is especially important if you have multiple lines in one single view, and there are different methods on how to do it. I'm gonna show a quick one and a professional one. So let's start with the quick one. Let's have multiple lines in our charts. I'm gonna take this time the country and put it on the colors. So with that, we got a one line for each value inside the country dimension. And now I would like to give the ability for the users to highlight one of those values. In order to do that, it's very simple. Go to the country over here, right click on it, and let's go to the highlighter. So here we have the option of show highlighter. Click on that. So with that, if you check the right side, we're gonna get small box in order to highlight the values inside the countries. So the users can go over here and select one of those values, for example Germany, and as you can see, Tableau gonna go and highlight the line of Germany and it's gonna blur all other lines. So this is really nice way in order to go and highlight different values in Tableau in order to focus on one value. So this is really great way in order to go and highlight one line, especially if you have a lot of multiple lines. So that was it. This is how you can create quickly a highlighted line chart in Tableau. Alright, so now we're going to talk about the second method on how to create highlighted line chart, but this time more professionally. So now I just duplicated the old line chart where we have the quarter, sum of sales, and the countries on the colors, but this time we're going to get rid of this highlighter, so I'm just going to go and remove it. So now we have to give the users a list of all countries in order to select, and this selected country going to be highlighted in the view. So in order to do that, we're going to go and create a parameter. So let's go to the data pane, right click over here, then create a parameter. So here we're going to give it a name, select country. Since the country values are string, the data type gonna be as well a string. And now next we're gonna go and create a list of all countries that we have inside the dimensions. So here we have 4 values. We have France. Be careful that you have exact case. So the first character is capitalized and the rest is small. So we have Germany, Italy, and the last one is USA. So that's it for our parameter. Let's go and hit OK. So with that, we get our new parameter on the left side. Right click on it and show parameter in order to see it here on the right side. Now the users can go over here and select one of those countries. But as you can see, nothing is changing in the view because we haven't connected yet to our view. Now, in order to connect it to our view, we have to go and create a new calculated field. So let's go to the data pane again, create calculated fields. Let's call it highlighted country. And here we can have a very simple condition where we're going to say country equal our parameter. So our parameter is going to be select country. So here what we are saying is that if the selected country from the parameters equals to the value of the country, then we're going to have true, otherwise it's going to be false. So for example, now we have the value France selected in the parameter. That means the country France gonna be true and all other countries gonna be false. Let's go and hit OK. So now we're gonna go and work highlighting the selected country. In order to do that, let's start with the coloring. So currently we have the coloring on the country. I'm gonna go and move it to the details. So that means now the countries are just creating the lines and not responsible for the coloring of the lines. Now in order to bring the coloring, we're gonna get our new calculated field, the highlighted country, and let's put it on the colors. So now we can see that we have only two colors because we have false and true. So if it's true, it's going to be orange. If it's false, it's going to be blue. But I would like to change those colorings to do the highlight effect. So let's go to the colors, edit colors. False going to be gray and the true going to be, let's say, for example, the blue. Let's hit OK. So now we get like a highlight effect. All other lines are gray and only the one that we selected is going to be blue. But now let's go and test our parameters. So we have here France selected currently. Let's select Germany, and as you can see now that selected line gonna be Germany. Let's take Italy and USA. So now as you can see, our parameter now is working. So now here we have a little bit issue where the highlighted line is behind the gray lines. So in order to switch that, I would like to have the highlighted in the front and the gray in the back. We're just gonna go to the legend over here. If you don't have it, you can go to the Aliases, and then here we have the option of the legends, and make sure to select the colors. So currently it's selected by me. So what we're gonna do, we're just gonna switch those two values. So let's take the true and put it on top. So with that, we have sorted those two values, and as you can see in the charts, the blue color in the front and the gray color in the back. And now the next step in order to create this highlight effect in Tableau is that we're gonna change the size. In order to do that, we're going to use our new calculated field. So the highlighted line, drag and drop it on the size by holding Control. And now with that, we got different size for the highlighted line compared to the others. But here we have the opposite effect. But we don't want that. We want the rest going to be thin and the highlight going to be heavy. So in order to do that, let's go to the legend over here. Just double click over here. And now as you can see, the true is thin, the false is heavy. In order to switch it, we're going to go to reversed. Let's click on that and hit OK. So with that, you can see the highlighted line is way heavier than the rest. You can change the size if you don't like it like this. So we can reduce a little bit the sizing and it's going to be now more nice. Alright, so that's all on how to create highlighted line in Tableau more professionally than the previous one, where you have more control on the sizing and the coloring. The users can go over here and start changing the value, and with that we are highlighting one line compared to the others. So that's it. Alright, next we have a fun one where we're going to build a pump chart using lines in order to do ranking between different values. So now, for example, I would like to rank the countries over time. In order to do that, we're going to have the same view where we have the quarter and the sales, and we have a line. So now the first thing that we're going to go and grab the country and put it on the colors in order to create those different lines. And now since the analysis is about the ranking, not the total sales, in order to build that, we're going to go to the sum of sales over here, and we're going to go and create a quick table calculations. Here we have the rank function. So let's go and select that. So now we have a ranking that depends on the whole table or on the whole view. I don't want that. I would like to rank between only 4 values. So in order to do that, let's go to the sum of sales over here, right click on it, and let's edit the table calculations. So let's go inside, and now instead of having table across, I'm gonna go and specify a dimension. So now we would like to have a ranking only using the country. So we're gonna have only 4 values. I'm just gonna go as well and deselect the order dates. So let's go and close this. So now we have some kind of effect of the pump chart, but we are not there yet. As you can see, the ranks like starts from the bottom to top. I would like to reverse it. In order to do that, right click on the axis, edit the axis, and then let's reverse. So that's all. Let's close this. As you can see, now we have the top rank at the top, and then the bottom we have the lowest rank. So now in order to have this pump effect, we have to have like circles inside our visual. We can do that very easily if you go to the... So now in order to have the pump effects, we have to have lines. We have it already, but as well we have to have circles on the data points. There is one easy way in order to do that. Let's go to the colors and change the markers to circles. So now as you can see, we got our small circles on each each data point and we get the pump effects. But now sometimes we go more advanced in these charts where we can make our own customizations for those circles, where we want to make those circles, those data points, a little bit more bigger and inside it the rank. So now in order to do that, let's first hide those small circles. We don't want that. So let's go to the colors and just have a line without markers. Now in order to have circles, we have to have the same measure again in our view. So let's take the sum of sales, hold Control and put it on the right side. So with that we got two charts for each measure. Let's go to the second one, to the sum of sales over here, and instead of having lines, let's move it to circles. So switch the marks here to a circle. So as you can see now we got very nicely those circles, and now we can go and change the size of those circles. Alright, so that looks nice. Now the next step is that we're gonna go and put it on top of each other's, and we can do that using the dual axis. So let's go to the sum of sales on the right side, right click on it, and let's select the dual axis. So now with that you have very nicely those circles on top of our line, but the colors are not correct yet because those two axes are not synchronized. So let's go to the right side, right click on it and synchronize axis. So now we got those circles perfectly in our lines. I would like to hide the right axis, so right click on it and let's hide the header. So now the next step we can go and add numbers on those circles. So I'm gonna stick with the second measure on those circles. Let's go to the labels and show label. And the next step I would like to add those numbers inside the circle. So go to alignment over here and then the vertical, and let's make it to the center. So with that we got those numbers inside the circles, and we can go as well and change the coloring and the font over here. Let's make it white. And now with the next step I would like to go and change the sizing again of those circles. So let's make it a little bit bigger until it looks nice. Alright, so that's enough, and with that we got a really professional pump chart, and we are controlling the size of those circles. So now we can go and very nicely check the ranks of those countries. As you can see, France was in the first data points, the rank number 1, then it dropped to 2, then 3, then back to 1, and we can see the development of those sales between countries. And we can see very nicely that Italy is always the lowest rank in the sales in our business. Alright, so this is how we can create pump chart in Tableau. Alright, so now we're gonna learn how to create sparkline chart in Tableau. Sparkline charts are really like compact visuals in order to show the trends, the changes over time, and you're gonna find it in a lot of dashboards in order to show KPIs. So now let's see how we can create that. It's really simple. So now we're gonna take a dimension like the country and put it in the rows in order just to split those lines to smaller size. So now in the sparklines, it's very important to have the informations of the sales at the start and at the end of each line. So let's go and do that. Let's take the sum of sales, drag and drop it to the labels over here, holding Control. So now we have the information of sales on each quarter in each data point. We don't want that. So let's go to the labels over here, and now let's go to the min and max. Let's go select that. So now we can see that we have for each line two values, the minimum and the maximum, but here it depends really on the sum of sales. So instead of that, I would like the min and max depends on the value of the order date. So let's go and switch that. We're gonna go to the field over here. Instead of automatic, let's select the quarter. So now as you can see with that, we got exactly our spark lines. We have the starting value and the end value of each line. But now usually the sparks lines are really compact visuals. They are really small lines. In order to change that, let's switch from entire view to standard. And now we're gonna go very carefully to the end of our axis until we get the resize of our mouse. Then now let's go and completely reduce it. So with that we got our compact lines. I would like as well to remove those lines in our chart. So right click on it over here and go to format. And then here on the left side, we're gonna go to the lines. We are at the rows, so I would like to remove those rows. So make sure to select the rows tabs, and removing those grid lines, we're gonna go over here and select none. And with that, we got really clean spark lines without any grids. And as well, we can go and hide those informations about the sales. So let's go right click on it and show header. Let's disable it. So that's it. Now I'm happy with that. We got a very nice sparkline chart in Tableau, and as you can see, they are compact visuals in order to quickly identify trends, which we usually use it inside KPIs. Alright, so now we're going to go more advanced on building visualizations in Tableau. We're going to learn how to create barbell charts in Tableau. Barbell charts are really amazing in order to compare two data points and find the differences between them. It's like before and after, and it works perfectly if you have categories. So now we would like to compare 2 years, 2021 and 2022, by the categories. So now let's start first with taking the subcategory, not the category, in order to have more values. And now next we need two measures, the first one for the year 2021 and the second for 2022. In order to do that, we have to go and create a new calculated field. So let's go to the data pane, click over here, create a new calculated field. And now I'm going to call the first one sales 2021, and the formula is going to be very easy. So we're going to use the if condition, if the order dates, but now we are talking about the year of order date. So let's move it to year. So if the year of the order dates equals to 2021, so now what can happen if the condition is correct? We're going to show the sales. So then sales, and otherwise it's going to be null. So that's it. Let's go and end it. So now in this calculated field, we will get the sales only if the year is 2021. Let's go and copy it because we need it for the next one. So that's it. Then hit OK. And with that, we got in the data pane a new calculated measure for the sales 2021. Let's go and create for the next year. It's going to be the sales of 2022. Paste the same calculation, but now we're going to say if the year is 2021, then show the sales. So that's it. Let's hit OK. So with that, we got our second measure for the sales of 2022. Now we want to compare both of those sales in our view. So let's take the sales of 2021 to our columns. And now in the purple chart, we're going to have like two circles and between them a line in order to find the differences. So first, let's start with the circles. Instead of having bars, we're going to go to the marks over here and change it to circle. So with that, we got in our view the first circle for the year 2021. What is missing now is the second circle. So in order to do that, we're going to go and get our sales 2022, move it to the axis in order to generate the measure values and measure names. So just drag and drop it over here. And now with that, we got our second point. So the first one, the blue one, is for 2021 and the second one is 2022. Alright, so with that, we have built the first part of the barbell charts where we have the starting point and the end point. So now in order to show the differences or the distance between those two values, we have to have a line chart between them. So that means we need now another type of chart inside our view. In order to do that, we're going to go and duplicate the measure values. So hold Control, drag and drop it and just put it beside it. So now with that, we have the same data on the left and on the right. On the right, we're going to have now different visual. So instead of circles, we're going to have a line. So let's go to the tab over here on the marks to the second one. And now we're going to go and change the visual from circle to line. So with that, we got our lines, but we are not there yet. I would like to have a distance between two values. In order to do that, we're going to take our measure name from the colors and we're going to go and put it on the path. So drag and drop it on the path. And with that, we got exactly what we want. We have now like a line between 2 points. Alright, so now the final step is that we're going to go and merge those two charts in one. So in order to do that, as we learned, we're going to use the dual axis. So let's go to the measure values over here on the right side, right click on it and dual axis. Let's select that. So now we got a perfect line to show the distance, the difference between the starting point and the end point. But now we still have small issues in the visuals. I would like to make those circles a little bit bigger. So let's switch to the circles and go to the sides over here and make it a little bit bigger. Alright, so that's enough. And now as you can see, the line is on top of the circles, which is not really correct. In order to make it in behind, we have to go and switch the order of those dual axes. So let's take the right and put it on the left. Alright, so with that, we got a perfect barbell chart in Tableau, and we can go and analyze the differences between two data points between the sales of 2021 and 2022, and we have this very nice line in order to indicate the distances between them. So you can see, for example, in the envelopes, there is no change on the sales between those 2 years, but if you go to the fonts over here, you can see a huge change on the sales between those 2 years, and in the visuals, it really indicates those informations. So that's it. This is how you create and why we create barbell charts in Tableau. Alright, so now we're going to go and build rounded bar charts. Previously, we have learned how to build bar charts, standard ones, but now we're going to go advanced and build rounded bar charts, and we will use lines in order to do that. I know it sounds a little bit strange, but let's go and build that. First, we're going to go and get, as usual, the subcategories in order to make a rank. And I'm gonna stick with the entire view in order to have the whole view over here. Then let's go and get the sum of sales to the columns over here. So now as you can see, this is very nice standard bar charts. So now instead of having those classical bars, we're gonna have rounded edge bars at the start and at the end. So how we're gonna do that? We're gonna go and have like a dummy value average of the 0. So now what we're going to do, we're going to go and merge those two measures in one single axis. So in order to do that, let's drag the average and put it on top of the sales over here in order to generate the measure values and names. So now we're going to go and compare the bar chart to a line chart. So let's go to the marks over here to the line. And then what we're going to do, we're going to take the measure name and put it on the path. So now we are almost there. What we're going to do, we're just going to go and increase the size of those lines. So let's just make it bigger, and with that, as you can see, we got rounded bar chart in Tableau. And as well, we're gonna get very nice color effect if we take the measure values, hold Control, and then drag and drop it through the colors. And with that, we got really nice rounded bar chart in Tableau. Well, if you ask about now the use case, it's exactly like having standard bar charts. For example, here we can make a ranking list of the subcategories. We just change the visual of it. So that's it, how you can build rounded bar chart in Tableau. Alright guys, so now we're gonna learn how to build sloppy charts in Tableau. Sloppy charts are perfect in order to show how the ranking is changing over time for different categories. So let's see how we can do that. Since the ranking over time, that means we need the order dates. So let's go and bring the order dates to our view. Then the next step, as usual, we're gonna get our measure, the sales, to the rows. So here we want to compare the last 2 years. So in order to do that, let's go and filter the data. So show filter for the years, and let's go and select the last 2 years. So now we have to decide which category you want to compare. You can go for the product categories, we can go with the countries. So let's go and pick the country and put it on the details. So now the next one, I'm gonna go and just make it a little bit bigger in order to compare those 2 years. The next step is that we're gonna go and put the category or the country on the names. So let's control on the country and drop it on the labels. So now we can see the country name on the end of each labels, but I would like to have it as well at the start in order to get the sloppy chart. So let's go to the labels. So now what we have to do is to put the labels at the line ends. So instead of having all, let's switch it to line ends and let's close it. So now we can see that each line starts with the country name and ends as well with the country name. And now the last step is that we want to add for each line like small circle. In order to do that, as we learned before, we go to the colors and we put the markers. So now we have a small circle at the start and at the end of each line, and this is the easiest way in order to build sloppy chart in Tableau. So again, the use case of the sloppy chart is that we can see how the ranks are changing over the time. So in 2021, you can see France first as a first, then USA, Germany, and the last was Italy. And now we can see the change over time. In the 2022, Germany went from place number 3 to be place number 1, and then France moved to number 2, USA moved to number 3, and as you can see, Italy, nothing's changed. So this is the power of the sloppy chart in order to see how ranking are changing over the time. And of course, in Tableau, we can go more advanced where we add more complicated stuff in order to have more customizations. For example, you say, you know what, I would like to have bigger circles. So in order to do that, we have to have 2 charts, one for the line and one for the circles. Let me show you how we can do that. Let's take the sum of sales, hold Control and duplicate it. So the first one gonna be the lines and the second one gonna be the circles. So let's go and switch for the second measure, and instead of automatic, we're gonna select here the circle. It's too way big for our visual. Let's go to the size over here and just reduce it in order to have smaller circles and as well a little bit more. So that's it. Now what we're gonna do, we're gonna bring those 2 charts in one. So let's go and merge it using the dual axis. So I'm gonna go to the second one over here, right click on it, and then let's go to the dual axis. Then if you look closely, those axes are not 100% synchronized. So what we're gonna do, we're gonna right click over here and then synchronize the axes. So now we got the circles exactly in the place that we need. So since we have two axes that have the same information, I'm gonna go and hide one of them. So let's go and disable the show header. And now you got the full customizations of the chart. You can say, you know what, for the lines, I would like to have another color. For example, let's have a gray color. Or you might say, let's make it a dashed line. So we go the path over here and move it to the dashed line. So with that, we get full customizations on our chart. But usually for the sloppy charts, we have a solid line between. So that's it. This is how we can create sloppy chart in Tableau. Okay, so now we're gonna learn how to combine different types of charts in one single view. And here we're gonna mix the bars with the lines. There are different methods on how to do that, depending on the use case. The first one is using the average line. So first, let's go and build a standard bar line over the time. So in order to do that, let's get the order dates to the columns and as well the sales to the rows. And then let's switch the years to a continuous month. So let's change the format. And now instead of having the line, we're gonna go and switch it to bar charts. So let's go to the marks and switch it to bars. Great. So with that, we have got our bar chart. The second step is to add a line. This line gonna be the average line. In order to do that in Tableau, it's very simple. Let's go to the analytics. And here we have the option of average line. Let's go and drop it to our view. So it's gonna be for the whole table. And that's it. As you can see, it's very easy. With that, we got a nice average line combined with the bar charts. Alright, moving on to the next method, we're gonna go and combine the bars and lines using the dual axis. And here we're gonna go and compare two different measures. So this time as a change, we're gonna go and compare the number of orders together with the number of customers. So now let's go and get the order date in order to see the changes over time. And then the next thing, we're gonna go and get the order, the count of the orders to the rows. And now let's go and change the format of the order date to months, and then change as well the chart to bars. So with that, we got our first chart, the bar chart. Let's go and get our second measure, and we're gonna have it as a lines. In order to do that, let's go the count of the customers, put it near the rows. So with that, we splitted our view to two charts. Let's go and change the second one to lines. So we're gonna go to the marks, switch to this page, and then now instead of having bars, we're gonna switch it to line. So now we have our two charts, the bar chart and the line chart, and as usual, we want to go and merge them together in one single view. So in order to do that, we're gonna use the dual axis. Let's go to the customers, right click on it, and then choose dual axis. So with that, as you can see, we have a bar chart together with a line chart. And of course, here with the dual axis, we can go to the right side and synchronize those two axes, but for now, it makes no sense. And of course, now we can add more customizations. For example, for the line, we can do the markers. So let's go to the colors over here and let's just add the markers to it. So that's it. Now we can go and start comparing the number of orders together with the number of customers in one single view using two different charts types. Okay, so now we're gonna build the bullet chart in Tableau. Here we're gonna combine again bars with lines. Bullet charts are really important in order to compare the current value with the target or compare the current year with the previous year. So now let's go and get, as usual, our subcategory to the rows. And now I would like to compare the current year with the previous year. So let's take the sales of 2022 from our data pane over here to the columns. And now let's go and sort it by the axis. So we have like a rank. And then we're gonna go and compare it to the sales of 2021. So what we're gonna do, we're gonna take the 2021 to the details, and then we're gonna go and add a reference line. So let's go to the axis to the sales of 2022, right click on it, and let's add a reference line. So now let's take it a little bit to the right side in order to see those reference lines. So what we're gonna take, instead of the sum of sales 2022, we're gonna have the 2021. So let's select that. And now we got one line for the average. We don't want that. We want to have the total sales for each subcategory. So in order to switch that, we're gonna go and say, instead of per pan, we're gonna have it per cell. So let's switch it. So now we got a line for each bar, which is great. great, but let's go and customize those informations. I don't want to see any labels, so let's go to the labels and switch it to none. And then let's go and format those lines. We're gonna go over here and let's take, for example, the orange color, and then let's go and change the transparency to 100% to have a full line, and then let's go and make it more heavy in order to see the lines. I'm just gonna go with the full, so that's it. So let's go and close this, and as you can see with that, we got very easily a bullet chart in Tableau where you can compare the current year of the bars with the lines of the previous year. So this is how you can create a very nice bullet chart by combining bars and lines. Alright, so now we're going to learn how to create a lollipop chart in Tableau. There are two types of that, horizontal and vertical. We can use this type of charts by combining the bars and the circles. So it's like a stick, and at the end we have a big circle, and we use the circle in order to highlight a data value. So let's go and create that. It's very simple. Let's take the subcategories to the rows, and then our measure is going to be the sales as usual. Let's put it on the columns. So with that we have already our bar charts. If not, then go to the marks and change it. Let's go and sort it in order to have a rank. So since it's lollipop, we're gonna have sticks, so let's have smaller bars. Let's go to the size over here and just reduce the size. So now what is missing in the lollipop is the end circle. So in order to make another chart, what we're gonna do, we're gonna take the sum of sales as well and duplicate it. So hold Control and just drag and drop the sum of sales. So with that we got our two measures, and what we're gonna do next, we're gonna go and change it to circles. So let's go to the marks, to the second sum of sales, and instead of automatic we're gonna have the circles. So now we got very nicely those circles, but they are really small. So let's go and make it bigger, little bit smaller. Alright, so maybe this is fine. So what is the next step in order to merge two charts together in one single view? As usual, we're gonna use the dual axis. So let's go to the second sum of sales, right click on it, and then let's go to the dual axis. So now as you can see, things got destroyed. We don't have any more the bars, and that's because in the first measure of the sum of sales, we didn't specify for Tableau that is bar. It was an automatic, and with that Tableau gonna go and make guesses on the suitable visual for the current data, which is something that is wrong. So what we're gonna do, we're gonna go to the first measure and say for Tableau it's not automatic, we want it always to be as a bar. So let's switch it. So with that, as you can see, we have already the shape of the lollipop. We have to do some few stuff that is not a big deal. So we forgot about synchronizing the axis. So let's go to the second one, right click on it, and let's synchronize it just to make sure that everything matches correctly. And now I have those two axes that have exactly the same information. So I'm just gonna go to one of them and hide those informations in order to have it only once. So now the key thing of the lollipop is that to show information at the end, at the circle. So here we can put anything, like any measure. For example, we can have the total sales or the total number of orders and so on. But in this example, I would like to have the text of the subcategory on those circles. So how we're gonna do that? We're gonna go to the circle over here and we're gonna put in the labels the subcategory. So by holding Control and putting the subcategories on the labels. So now as you can see, we have now the headers informations on those circles. So what we can do, we can go now and hide those informations. So right click and show header. With that, we have removed those header informations, and we have now the header informations or the subcategories on the circles. One more thing that we can do, we can go and add coloring. So let's take the sum of sales and put it on the colors. So with that, we have a really nice rank chart for the subcategories. Okay, so now let's see quickly the second type. We can have a vertical lollipop chart. I just duplicated the previous one, and all what we're gonna do, we're gonna go to the quick menu over here and switch everything between the rows and the columns. Alright, so now we have everything vertical, but we have really big circles, so let's go and change that. Let's go to the second sum of sales and go to the size. Let's try to reduce stuff over here, and we're gonna reduce as well the sticks. So let's go to the first sum of sales, to the size, and as well let's try to reduce the sticks. So now it looks really nice, but still we have a problem with the labels. So let's go again to the circles, go to the labels, and we're gonna change the alignment from automatic to on top. So we're gonna go and change that. So now we have the labels on top of those circles, but still we don't have all the labels because the size of the text is really big. So let's go to the fonts over here, change it from 10 to 8. One of them is missing. You can go and reduce the size of the circles. So that's it. This is how how you can create lollipop charts in Tableau. And here you can see the power of Tableau. We can go and combine different type of charts in one single view. Like here we are combining the circle with the bars. So that means we have endless amount of combinations, and this opens the innovations in Tableau where you can create amazing charts and visuals. And this is exactly the magic of Tableau. Alright, so now we're going to talk about the area charts in Tableau. They are like the line charts. We can use it in order to see how the data are changing over the time. But under the line, we're going to get a filled area in order to make it easier to visualize those numbers. So now we're going to start with a very basic area chart in Tableau. Since it is changed over time, we're going to get the order date to our view. And then as usual, we're going to get the sum of sales to the rows. And instead of year, we're going to switch it to month continuous. And now here we have it as a line because it's automatic. If you go over here to the marks, you can see we have a chart type called area. Let's go and switch it. So this is the most basic area charts that we have in Tableau. Okay, so now you might say, you know what, the basic area chart in Tableau don't have a line. And usually the area chart has a line, and between the line and the axis, we have like a filled gap. But the basic area chart in Tableau don't have this visual. In order to recreate this design, what we're gonna do, we're gonna go and create a line on top of our area charts. So here we're gonna have two types of charts, the line and the area. So let's go and create that. We're gonna take the sum of sales and duplicate it by holding Control. So now we have our two charts. The first one gonna stay as an area chart. The second one gonna be a line chart. So let's go to the second one of the sum of sales. Instead of area, we're gonna have a line. And I think you already know the next step. We have to go and merge those two charts in one single view. So how are we going to do that? Using the dual axis. So let's go to the second sum of sales, right click on it, and let's choose dual axis. And now the next step, we're going to go to the area chart and just reduce the opacity. So let's go to the colors, and now let's go and just reduce the opacity. And with that, we're gonna get a perfect area chart in Tableau where you have a line, and between the line and the axis, you have a filled gap, which is way better than the basic area chart in Tableau. Alright, moving on to the next one, we're gonna have the stacked area charts. It's like the bar charts. We can add more informations to our visualizations by adding the dimensions to the colors. So now we have the basic area chart at the start where we have the sum of sales and the month over the time. So now we're gonna go and add a dimension. Let's take the category and put it to the colors. So with that, we got three area charts stacked on top of each other's because inside these dimensions, we have three values. So what we can do over here about the design, we can go to the colors over here and increase the opacity. So really that's it. This is how you can create stacked area chart in Tableau. Alright, so next we're gonna go and build full 100% stacked charts. So here, if the total of the sales is not important, but what is important is to go and compare those different categories together, we can go and use the full stack charts. So let's see how we can do that. So we're gonna go to the sum of sales and we're gonna switch it to quick table calculations, percent of total. So let's go and click on that. We are not there yet. As you can see, we have the percentage over here on the left side. We want to have it from 0 to 100. So in order to do that, we're going to go again to the sum of sales, right click on it, and let's edit the table calculations. And now what we're going to do, we're going to switch it to specific dimension, and this dimension is going to be the category. So let's deselect the month of order date and let's go and close it. So with that, you can see the area now start from 0 to 100. And you have it like one block. And now we can go and very easily compare the three different categories. And here we can see very clearly how each category is relating to the whole, to the total sales of each month. So this is how you can create very easily a full or 100% stack chart in Tableau. Alright, so now we're gonna go and create small multiple area charts by adding multiple dimensions. So now let's go and get the first dimension. It's gonna be the country to the columns. Let's go and get the order dates as well to the columns, and then to the rows we're gonna go and get the categories. So those are our three dimensions, and then I'm gonna go switch this from standard to entire view. Now let's go and get the numbers inside our view. So it's gonna be the sum of sales. Let's put it in the rows. So as a default, Tableau gonna show it as lines. Let's go and switch it two areas to the marks. So with that we get our mini area charts in Tableau. But now let's add more details where we want to see the months. So let's go to the year over here and change the format to continuous month. So let's switch it. And then next we're going to go and add the coloring. So let's control and drag and drop the country to the colors. And in such visualizations, it makes no sense to have those grid information. So right click on it. Let's go to the formats, to the lines. Make sure to select the rows and then the grid line over here and make it none. So with that, we have created small multiple area charts in Tableau. It's very similar to the lines or to the bars. Okay, so now we're going to learn how to create the scatter plots in Tableau. Scatter plots are one of the fundamental charts in order to understand the relationship between two continuous measures. So that means the main task of the scatter plots is to find correlations between two continuous fields. And as well, another task of the scatter plot is to find the outliers inside your data. So let's go now and create a very basic scatter plots in Tableau. And as I said, we need two measures in order to do that. So our two measures going to be the sales and the profit. So let's get the sales to the columns and as well the profit to the rows. So with that we got our two axes and it's gonna represent a two-dimensional graph. So now what is missing is of course our data, the data points. So here we're gonna go with the customer ID. So let's take the customer ID and now we're gonna go and put it to the details. And here is the power of Tableau compared to any other tools, where Tableau gonna go and plot all data points that we have inside our data without any restrictions. So with that we can see the correlation between the sales and the profit, and as well to find the outliers, for example those points that we have it as a standalone. Alright, so with that we have created the very basic scatter plots in Tableau. Alright, so next we're gonna go and add more stuff to the design of the scatter plots, where we're gonna change the colors, the size, add circles and so on. So now we're gonna go and change the size of each data point, but it's gonna depend on a third measure, the count of orders. So now let's go to the orders count and drag and drop it to the size. Each customer is gonna has different size, and that's gonna depend on how many orders did this customers place. So this is one thing that we can add to our scatter plot. Another thing, we can add coloring. So here we have different ways on how to add colorings. Either we can add a dimension or we can make a cluster. So now for example, let's go and get the dimension country and place it on the colors. And here in the data points we can add as well different shapes in our visual. So currently we have the circle for everything. We can take the country, drag and drop it to the shapes, and now we can see in the scatter plot not only that the countries has different colors, but they have as well different shapes. But what we usually see in the scatter plot is that each data point can be represented as a filled circle. So that means we're gonna go and change the visual. Let's go to the marks over here and then change it from shapes to circles. So now as you can see we have everything as a filled circle, but we are not there yet. Let's go and make the size a little bit bigger. And now what do we have over here? We have a lot of points, and what we usually do, we go and reduce the opacity of the colors. So let's go to the colors over here and let's just reduce it, and with that you can see very nicely, for example those 2 points, there is like overlapping between them. One more thing that we can add to those circles, we can have like a line border for each circle. So in order to do that, we're gonna go again to the colors, and here we have an effect called border. So instead of automatic, let's have something like this color, the gray. So with that, you can see we have a very nice border for each data point. Alright, so those are some different options on how to customize the scatter plots. Okay, so now we're going to create the dot plot in Tableau. Dot plot is one-dimensional graph in order to see the distribution of your data between different categories, and each dot going to be representing one data point. So now let's go and see the sales by the order date, and then we're going to have the order ID as a detail. So we're going to take the order date to our rows. So now we're going to go and see the distribution of order IDs by the date. So let's take the order date to the rows this time, and let's go and change it to a month as a continuous. Then we're gonna go and get our measure to the columns, and now as a default we have it as a line. Instead of that, we're gonna go and make it as circles. So now we are not there yet, we have to add more details to the view, and that by moving the order ID to the details. So now since we have a lot of orders inside our datasets, Tableau gonna ask us, do you really want to do that? Well, yes, add all members. So now as you can see, we have a very nice dot plot. We can add more informations, like for example, let's take the category and put it to the colors. And as well, since there are like a lot of overlapping, we can go to the colors and reduce the opacity. So now with that, each data point, each circle gonna represent one order, and you can see now very clearly and very fast which orders has the most sales. So this is how you can create dot plot in Tableau. Alright, so now we're gonna learn how to build circle or bubble timeline. We usually use the circle timeline in order to analyze the changes over time, and we usually use it to show the distinct values of different circles across multiple categories. So let's see how we can build that. Since we said it is change over time, we need a date. So let's go and get the order date to the columns, and then we need one more dimension. Let's take for example the subcategories to the rows, and then we need our measure. It's gonna be the sales, but now instead of dropping it to the columns or to the rows, we're gonna drop it on the size, since each data point gonna has different size. So Tableau gonna show it as squares. Let's go and switch it to circles. And now in order to have more data points in our view, we're gonna go and switch the years. Let's take for example the quarter as continuous. So let's click on that. So now I'm gonna go and change the size of our view. I'm just gonna go to the header and make it a little bit bigger. And then we're gonna go to the axis and just make it a little bit smaller in order to have some overlapping. So now let's go to the size and increase the size, or make it a little bit smaller, and then we're gonna go to the colors and reduce the opacity. And now we can add more customizations about the design. Like for example, let's take the sum of sales and put it to the colors, and then let's increase as well a little bit the opacity so it looks better. And as well, depend on how you like it, maybe you can go and add some borders. So let's go to the borders over here. I like the dark one, so maybe I'm just gonna go and make it more gray, because here you can go and customize different stuff. For example, you can go and use two measures. So for example, instead of having the sum of sales on the colors, we can go and get the sum of profit. So let's go and get the sum of profit on the coloring. So now we can see in this one chart, we can see a lot of stuff. The change over time, we can see as well the coloration between two measures in order to understand the relationship between them, where the size gonna indicate the sales and the color is gonna indicate the profit. So this is really powerful and very great analysis in Tableau using the circle timeline. Alright, so now we're going to talk about the pie chart in Tableau. It is very easy and common way in order to analyze or show the part to whole data. So let's see how we can build that on Tableau. There is like an easy way or sheeting way in order to do that. If you go to the show me over here and then click on the pie charts, we will not do that. We will create it on our own so that we understand how Tableau works. So let's not take the shortcuts. I'm just going to close it. So in order to build a pie chart in Tableau, first let's go to the marks over here, change it from automatic to a pie. So with that we get a small icon called angle, and here we're gonna go and drop our fields on top of it. So here in this example we're gonna build a pie chart from the sales and then split it by the country. So let's take the sales and put it on the angle, and with that we got our first chart. It is like a circle and it's not divided yet. Let's switch from standard to entire view in order to get a bigger pie chart. And then the next step, we're gonna go and divide this pie chart into sections. So our dimension gonna be the country. Let's go to the customers, then grab the country and let's put it on the colors. So with that, our pie is divided to multiple sections, and the size of each section can indicate the sales of the country. And this type of charts is used in order to analyze the part to whole. So for example, here we can analyze how the USA is contributing or relating to the whole of sales. So as you can see, it's really easy to build and very commonly used in many dashboards. We can go over here, for example, and add some labels and change the design, of course, of these pie charts. And one more thing that I would like to show you is that sometimes in the dashboard you can see that there are multiple pie charts in one dashboard, in one view. In order to do that, you just grab any dimensions and put it to the rows or to the columns. So for example, let's take the category and let's put it on the columns. And with that, we got immediately 3 pie charts under those 3 different categories. So this is how we usually deal with the pie charts. We have one dimension that split the pie charts and another one that is duplicating those pie charts. Alright guys, so that's all for the pie charts in Tableau. Okay, so now moving on to the next one, we have the donut chart. Donut chart is very similar to the pie chart. You still have this analysis of part to whole, you have a circle and you have different segments, but many people prefer to use the donut chart, and that's because we can add an extra informations to the circle. Alright, so now in order to build it, we need two charts. The first one gonna be the pie chart, and the second one gonna be the empty space in the middle. So let's start with the pie chart. As we learned previously, we have to switch the automatic to a pie chart. Then we take our measure, gonna be the sum of sales to the angle, and then next we're gonna take the divider, it's gonna be the country to the colors, and with that we got our pie chart. Okay, so now next I'm gonna switch from standard to entire view. So this is for the first chart. Now in order to get the empty circle in the middle, we have to create another chart inside this view. So now we're gonna go and create our empty measure just to have a second chart. So in order to do that, let's go to the columns over here and write average of 0. So now we're still in the marks, we have only one visual. In order to get a second one, we will go and duplicate it. So now with that, we got our two measures, one for the pie chart and the second one gonna be for the empty space. So now what we're gonna do, we're gonna go and merge those stuff together in one place because we have to have only one donut. So right click on the average and let's go to the dual axis. And as usual, we're gonna go and synchronize stuff. So let's go and synchronize the axes. And now let's go and get rid of them. We don't want them, so show header away and as well from the bottom. So now we have the two charts in one place. It's a little bit small, so let's go and make things a little bit bigger. So let's go to the sizes and just make it bigger in the middle. Alright, so now let's go and make the empty space in the middle. So let's switch to the second marked over here. And now the second chart, it will not be a pie, it's gonna be like a circle. So let's go and switch it to a circle and let's get rid of all those informations. And now if you check our view, we don't see the pie chart, and that's because we have overlapping and the pie chart is behind our circle. So now in order to show it, what we're gonna do, we're gonna go to the circle, go to the size, and now let's go and start reducing the size of the circle. And as you can see, now we are getting the shape of donuts, but our donut should has in the middle a white color. So let's go and change the circle color to white. Perfect. Now we got the donut shapes in our view, but now let's go and get rid of all those lines. So right click over here on the empty space, go to format, then let's go to the left side. Let's start with the lines over here. So the 0 line, let's go and switch it to none. And then we still have on the column one more line. Let's switch to the columns. Instead of the grid line, let's move it to none. And then in order to get rid of those borders, let's switch to the borders. Then let's go to the row divider, make it none. And as well for the column divider, it's none. And with that, we got very clean donut shapes in Tableau. Now let's add some labels and some data to our donut charts. So let's go to the pie chart first. Here we're gonna get the informations of those sections. So what we're gonna do, we're gonna bring, for example, the country to the labels. And as well, we can go and get the sum of sales, like hold control and drag and drop it to the labels as well. Now we can go and change the font format, of course, if we go to the labels over here and then click on the 3 dots. Then let's make, for example, the sum of sales bold, and that's it. So far there is nothing new compared to the pie charts. We are just showing the informations of each sections. But now here comes the power of the donut charts. We can give an information here inside this white circle, and it's gonna be usually the total of the measure, the total sales. So now let's go and switch to the circle over here. Let's go and get the sum of sales and put it to the labels. Now you can see the sum of sales here strangely on the right side because we didn't customize it yet. So let's go to the labels and then let's go to the alignment over here and make it everything to the middle. So with that, as you can see, we got the total sales in the middle. Let's go and customize the text a little bit. So let's go inside. So now what we're gonna do, we're gonna write the total sales at the start, and then we're gonna make everything like bold for the real number, the real values, and let's make everything a little bit bigger. So 16, and click OK. So now as you can see, we got now another information to the bar charts where we have the total sum of sales in the middle, and then we can see very nicely the different sections around this number. So that's it. This is how you can create donut charts in Tableau, and this type of chart, it is like way more used than the pie chart since you can add one extra informations in the middle. Okay, so now we have another chart in order to analyze the part to whole using the tree map. We usually work with the tree maps in order to show the hierarchical data inside our datasets. So let's see how we can build that. Let's first start with the marks. Let's go and switch it to squares. The next step, we're gonna go to the sales and we're gonna put it on the size. With that, we got one blue square for the total sales inside our data. Now, of course, we want to go and split this square to multiple informations, and here we're gonna work with the hierarchy of the products. So let's start with the first dimension, the category. Let's drag and drop it to the colors, and as you can see, we already got now a tree map. So the colors of the tree map is decided from the category, and the size of those blocks gonna be decided from the sales. Now, of course, in this tree map, we want to represent the hierarchy, so the next dimension gonna be the subcategory, but this time we will not move it to the colors, we will move it to the details. So let's go and do that. So now, as you can see, each of those blocks are divided to more blocks where we have the subcategory informations. So that means the data will keep splitting in the tree map the more dimensions we add from the hierarchy. So for example, let's go and grab the product name and let's put it to the details. And now we can see that we have a lot of mini blocks that represent the product name. So with that, we have represented our hierarchy of the product in a visual, in a tree map. And we can see that each category, for example, the red, is split into multiple subcategories, and each subcategory is split furthermore to products. But of course, the disadvantage here is that the more details you add, the harder gonna be to read this visualization. So I don't recommend you to go with the product name in such a visualizations. It should be enough with the category and the subcategory. And of course, like any other charts in our visualizations, we can have multiple tree maps in one view by adding a dimension to either columns or rows. Like for example, let's go and get the order date to the rows, and with that we got multiple tree maps splitted by the years, which is really useless to have such a visualization. So let's go and remove it. Okay, so now we're gonna talk about the heat map. It is like a matrix where you have colors inside it, and we usually use it in order to do colorations between two categories. So let's see how we can build that. We need two categories, that means we need two dimensions. So let's say the first one gonna be the country. Let's drag and drop it to the columns. And then the second dimension gonna be, for example, the subcategory. Let's drag and drop it to the rows. And with that, we got our matrix. Let's switch to entire view. So we have rows, we have columns. Now what is missing, of course, is our measure, the data. So now in order to create the effect of the heat map, we're gonna take the sum of sales and let's put it to the colors. And now with that, we got our heat map, and we can see from the colors the coloration between the countries and the subcategories, where we can see immediately that the highest sales where we have the dark color. So for example, we have high sales from the country France and as well from the subcategory phones. And the lowest sales, we can see it, for example, here in the envelopes and Italy, where here we can see again the power of visualizations, where we can read now the trends and the colorations between our data, which is way better than having only numbers. But of course, if we want to add some numbers in this matrix, we can go to the labels over here, show marks, and if you want to make it to the middle, let's go to the alignments and let's make everything in the middle. So that's it. As you can see, it's really simple, and this is how we can create heat map in Tableau. Bubble chart in Tableau, they are a really great way in order to add a lot of dimensions and measures in one single view. So bubble charts are like circles, and we can define a lot of stuff in the circle, like the colors, the size, we can put inside it a text. So let's have an example. We're gonna start with the marks. So instead of automatic, let's go and switch it to circles, since the bubbles are circles. So let's start with the first information. We're gonna go and get the measure sales, and let's put it on the size. So with that, we got our first small bubble or circle. Let me switch it to entire view. So now we have one information, the total sales inside our data. Let's add another information like a dimension. So let's go and add the subcategories inside our view. So I'm gonna take this dimension and let's put it on the details. So now, as you can see, we got more bubbles, and we're gonna get a bubble for each subcategory now. Alright, so now let's keep adding more informations to our bubbles. Let's say that I would like to add the coloring for the bubble, and this should come from another measure. Let's take the profits and let's put it to the colors. So now with that, we got different colors depends on the values from the profit. And now how about to add one more information inside those bubbles? Let's say the category. So let's go and get the dimension category, and now let's put it on the labels. So now we can see the category of each bubble of each subcategory. So now as you can see, we have 4 different informations that we have inside our bubble. The first one is the colors of the bubbles indicates the profits, and then the size of the bubbles show us the sales informations, and then the number of those bubbles are decided from the subcategory. So we have all those subcategories inside our data, and finally the text inside the bubble comes from the category. So this is the power of the bubble chart, where you find a lot of informations in one view. Okay, so now we have another fun one called stacked bubble charts. So here we're gonna add a lot of dimensions in the details. So let's see how we can build that. Let's go to automatic as usual, then switch it to circles. Let's take the sum of sales and put it on the size. We are just creating again our bubbles, and this time we're gonna go and get the country and let's put it to the colors. So far we have those 4 colors for 4 countries. So now if we bring any dimensions to the details, it's gonna split these bubbles to more small bubbles, and that's depend on the cardinality of the dimension. For example, let's take the category. It has very small cardinality, and with that we will get just few bubbles. So if we go and remove it, let's take the subcategory. And now as you can see, we are getting way more bubbles than the category, and that's because we have more data inside the subcategory. And now let's go with higher cardinality. So let's just remove the subcategories and let's get, for example, the product name. So once you do it, you will get a lot of small bubbles and they are all stacked together. And of course you can go and sort the bubbles differently. If you go to the country over here, right click on it and let's go to sorts. Let me just move it to the left side a little bit, and if you change the sort, as you can see, the color is going to change as well. So here you can go and sort the bubble as you want. And now of course we can go with more details if we take the lowest level of details, the order ID. So let's drop the product name away and let's go and get the order ID. And with that, Tableau can ask us, do you really want all of those data? Yes. Add all members, and now you will get for each order a small bubble inside our visualizations. Okay, so this is another way on how to represent your data in visuals using the stacked bubble chart. But if you look at it, you will find it's look like the Sauron eye. Alright, so that's all for the stacked bubble charts. Okay, so now we're going to talk about Tableau maps. First, let's get the data in order to plot the maps. So let's go and create a third data source. I am at the data source page. Let's go over here in this small icon, new data source, and then let's go to the text file and then to the data that we downloaded. So let's go to the big folder, and then we have over here USA sales. So let's select this CSV file and click open. So it's really simple table where we have the orders, country, region, state, and sales. So that's it. Let's go back to our view and let's create now a very basic map in Tableau. So again, we can go and cheat using the show me, but we're gonna go and create it from scratch. So now if you have a look to our data pane, you can find that we have 2 automatically generated fields, the latitude and the longitude. They are geographical coordinates in order to plot the map, the Earth. So the latitude is responsible to plot the horizontal lines, and the longitude is responsible to plot the vertical lines. So what we're gonna do, we're gonna go and use them to the columns. Let's take the longitude to the columns and the latitude to the rows. So with that, you can see that Tableau is now able to plot the Earth. And now next we have to specify for Tableau the country, the states, those geographical informations. So let's take, for example, the country to the details. And with that, you can see that Tableau is now focusing only on the United States because we have only informations about USA. So now let's take the states as well and put it to the details. And now as you can see, Tableau is focusing now with those points on each state. Alright, so now the next step, instead of having circles, I would like to have a map chart. So let's go to the marks, switch it from automatic to map, and with that we have the whole area covered with the colors. So now you can go and add coloring depending on the dimension that you want. So for example, we can go to the region over here and put it to the colors. So now we can see that the map is now splitted by the regions. So now what is missing here is the sales informations. So let's go and get the sales, but here we have a small problem that the sales is a dimension and discrete because of the data type. So let's go and switch it to a number hole and then make it continuous. So convert it to continuous, and then the last thing, we have to convert it as well to a measure because it's still as a dimension. So everything is fine. Let's go and get the sales to the labels, and with that we got very nicely the total sales for each state. So this is how you can create a very basic map in Tableau. Okay, moving on to the next one, we can create maps in Tableau with symbols. So I just duplicated the previous one. Let's go and switch the visual from map to, for example, circles. And then the size of the circle gonna be decided from the cells. So let's take the cells and put it to the size. And then the next step, let's go and make the circles a little bit bigger. And now we can add another measure to the circles. Let's say the number of orders. We're gonna take over here the count of the USA sales CSV. So let's take it to the colors. So now the scale of the color gonna define the number of orders, and the size of the circle gonna be defined from the cells. So this is one way in how to represent those informations as circles or bubbles. We can go and choose different shapes. So let's go over here in the marks and go to the shapes. You can go, for example, with, let's say, what we can have over here. Let's go with the stars. So as you can see, we have here a lot of options on which symbol can be presented inside our map. So this is how you can add symbols to the maps in Tableau. Alright guys, maps in Tableau are very rich in the customizations. There are a lot of options on how to plot the maps in the view. So now I'm going to show you a few possibilities on how to plot the maps in Tableau. The first one is about how to have a map without any background noises. So now let's go and do that. If you take the country field and just drop it here in the middle, Tableau going to understand we are talking about map, and we're going to get automatically everything inside the columns and the rows. So now the next step, let's take as usual the states over here, and then we're going to go and color it with the region on the colors. So now if you check the map, you can see there are a lot of grayed out areas inside the map that is not used directly. So if you want to remove all those informations, what we're gonna do, we're gonna go to the main menu. You have here maps options, and then here we have a background layers. Let's go and click on that, and then here on the left side we will get many options on how to customize the maps. I really recommend you to go and click around. It's really fun to work with maps in Tableau. So now the task is to remove all those background informations. What we're gonna do, we will just remove all those selected informations. So let's just remove everything, and with that, as you can see, we have removed the background and we have only the relevant informations inside our view. And there is another way on how to remove the background. Let me just go back with all those settings. So I think with that we got all informations back. Another way to remove the background informations, to go to the washout and move it from 0 to 100. So now as you can see, the background inside our map did disappear. So this is how we can remove the background informations inside our map, and you get really a clean map in order to focus on the relevant data. Okay, the next one is as well about customizing the maps in Tableau. So now let's go and create a night vision map. It is just fun to work with maps in Tableau. So let's go again and get the countries in the middle, the states to the details. So now in Tableau we have different types of maps, not only one. So if you go to the main menu over here to the maps, either you check the background map, so here we have the different modes, or if you go again to the background layers, and on the left side you can see here the styles. So currently it is white and gray, it's light. So if you click over here, you can find the different modes. We have the normal one, and then we have stuff like dark, street, outdoors, and satellite informations. So it's really nice to have different styles. What we're gonna do now, since it's night vision, we're gonna go with the dark modes. So now the next thing, I would like to reduce some informations like United States and Mexico. Let's go and remove those stuff from the left side. And then what we're gonna do, we're gonna go and add some measure to our view. So let's close the background layers over here. Let's go and get the sales to the size. So with that, you are getting those nice circles. Let's make it a little bit bigger. And then we can add the sales as well to the colors. So hold control, put it on the colors, and let's change the coloring. So let's go and edit colors. And now let's go to the automatic over here and let's change it to another pattern. For example, let's take the blue-green over here. Click OK. Okay, so now we're gonna go and add more customizations to our map. For example, let's say that I would like to change the color of the borders for those states. So I would like to make it red in order to make it more interesting. I cannot do that in the current view because if I change anything about the border, it's gonna change the border of the circles and not the border of the states. So in order to do that, we need two maps, one for the circles and one for the states. Alright, so now let's see how we can do that. We're gonna go to the longitude and we're gonna go and duplicate it. So now with that, we got two maps, the left and the right. Let's go and configure the right one. So let's switch the marks to the second map. And now instead of having circles, we want to have a map. So let's switch it to a map. So now as you can see, now we have two different types of maps, but now I would like to have only the border information. So I'm not interested about the sale. So let's go and remove it, and as well for the sizing. And now as you can see, we have gray colors that is filling the map. So let's go to the colors and reduce the opacity to 0%. So with that, we don't have any colors on the map. What do we need is the color of the border. So let's go again to the colors. Let's go to the borders over here. Let's make it red. I'm not really happy with this color. I want it to be more red. So let's go to more colors and let's get the re-red. And now the question is how to merge those two maps in one map. Well, the answer for that using the dual axis again. So let's go to the right one over here, right click on it and dual axis. Alright, so with that we got one map, but I'm still not that happy. You can see that the circles are behind the lines. In order to have it in the front, let's go and switch those two measures. And now you can see that the circles are in the front. Alright, so with that we have created our night vision map, and with that you have learned as well how many possibilities that we have in Tableau in order to customize the maps. All those different options that we have inside the maps, I really recommend you to go and explore those options that we have inside Tableau. It's really fun. Okay, so now we're gonna learn how to create histograms in Tableau. There is two ways, one quick way and one advanced way. The quick way if you have one measure, the advanced way if you have two measures. The histograms are a really great way in order to show the distribution of your data using bar charts. So let's see how we can do that. Let's work with the one measure, the quantity. So right click on it and then go to create and then to bins. And here we can go and configure our bins. I'm gonna leave it as a default as Tableau suggests. So let's go and click OK. With that we have created a new bin, a new dimension in our data pane. So now what we can do, we're gonna go and grab it to the columns, and here you can find the size of our bins, and then we're gonna go and get the quantity to the rows. And then the next and the last step, what we're gonna do, we're gonna go to the quantity and convert it from discrete to continuous. So right click on it and switch it to continuous. So with that we have created a very simple and nice histogram to see the distribution of our data using the measure quantity. Alright, the next one is going to be a little bit more advanced, where we're going to create a histogram using two different measures, the number of customers by the number of orders. So we want to cluster our customers based on the number of orders that they placed. So now in order to do that, we have to create our bins, but now we're going to use the calculated field in order to do that using the LOD expressions fixed. So let's see how we can do that. Let's go and create a new calculated field. Let me just move it a little bit over here. So what we're going to find out is the number of orders per customers. So in order to do that, we can use the LOD function fixed. So it starts with fixed. Let me select that. And then for each customers, we want to count the number of orders. So for customers, we're going to get the customer ID, and then the aggregation is going to be the number of orders. So that means we're going to go and count the order ID. Alright, so that's it. Let's go and hit OK. So with that, Tableau did create a continuous measure, but I would like to convert it to a discrete dimension. So right click on it and let's convert it to dimension, and that's it. So now let's go and grab it to our view and check the informations. Alright, so with that you can see that we have already our bins, and those are the different number of orders that the customers did order. So the next step, we need our second measure. It's gonna be the number of customers. So let's go to the customers count over here, drag and drop it to the rows, and as well let's take the customers to the labels, and with that we got a very nice histogram in Tableau using two measures. So again here, if you want to build a histogram from two different measures, one of those measures has to be the basics, the bins of the histogram, and the second measure gonna be used in order to do the counts. So now we can see very quickly that most of our customers are ordering between 13 orders and like 16 orders. Alright, so those are the two methods on how to create histograms, the easy way and the little bit complicated way. Okay, so now we're gonna learn how to create calendar in Tableau. So now we're gonna go and build this calendar using the order date. So let's take the order date first to the columns. And now in the columns, we have to have the days. So right click on it in order to change the format, and then go to more, and then let's get the weekday. So with that, we got the Monday, Tuesday, and so on. Then we need to build the rows of the calendar, and it's gonna be the week number. So let's go and hold Control, duplicate it to the rows. Instead of the weekday, let's switch the formats again to over here to the more and then week number. So with that we got our matrix, our calendar, but as you can see we have here all the weeks. I would like to reduce it to only 1 month. So that means we're gonna go and add some filters to our view. Let's take the order date, put it on the filters, and the first filter gonna be on the years. So go and select the years. And let's select the last year, hit OK, and we can of course go and offer it for the users. So right click over here and show the filter on the right side. We're gonna do the same for the months. So let's go and take the order date and put it on the filters. Let's go for the month next, and let's select only 1 month and then offer it as well to the users. Alright, so with that we got a calendar of 1 month. Let's go and switch it from standard to entire view. So now as usual we need a measure in order to fill our calendar. It's gonna be the sum of sales, so drag and drop it and put it on the colors. Alright, so with that we can see already that we have a heat map inside our calendar. Now we need to just add few stuff. For example, let's add some white border between those informations. Go to the colors and then go to the border and add a white color so that we get nice separations between the days. And let's add as well the day number in each box. So in order to do that, we're gonna go to the order dates, put it on the labels over here, and then here Tableau switch it automatically to a text. Let's go and switch it back to squares, and instead of having the years we have to go and format our date. So right click on it and let's go and select the day, and then the next step, let's go and place those numbers of the days on the top right corner. So let's go to the labels, alignments, and let's go to right and then top. Alright, so with that we got a really nice calendar in Tableau. Of course you can go and switch to another month, let's say for example in February, or check another year, 2021, and that's it. This is how you can create calendar in Tableau. Alright, now we're gonna create in Tableau the waterfall charts. It's very useful in order to show the flow of the process of your data and as well to show the analysis of part to whole. So let's see how we can create that. First we need a dimension like the subcategories. Let's move it to the columns, and then we need a measure. This time let's take the profit, drag and drop it to the rows, and then let's change it from standard to entire view. So now in order to have a waterfall inside our view, we need the running total. In order to do that, let's go to the profit over here, right click on it, and let's do a quick table calculations, and let's switch it to running total. So with that you can see we have now a running total of our data, but still it is not a waterfall. So in order to do that we have to switch it from the classic bars, so let's go to the marks over here, to the Gantt bars. Alright, so with that we got the basics for our waterfall, but now the size of each line gonna depend on the profits. So let's go again and grab the profit to the size, but now if you check it closely we can see that those bars are not making the waterfall because they are in the opposite direction. We would like it to be starting from 0 from the bottom to top. So in order to make this effect, let's go to the sum of profit over here, double click on it, and then let's make it as a minus. So click on that, and now exactly we got what we want. So it starts from the bottom to up, and with that we are forming the shape of waterfall. So now we have to add some coloring. So let's go and get the profit, put it on the colors, and now what we want to do with the colors, if the numbers are positive then it's gonna stay blue, but if it's negative it should be red. So in order to do that, let's go to the colors and edit colors. And now we're gonna do the following setup. So let's go over here and make it only 2 steps. And then let's go to advanced over here and make sure that everything in the center. So it is 0 over here. And that's it. So let's go and hit OK. And with that, we can see very easily where are the negative values in our waterfall and where are the positive values. You can of course make it as green and red. So now the last thing that we have to add to our waterfall is the total. In order to do that, it's really simple. Let's go to the Analysis on the main menu. And then we go to the totals over here. And let's add show row grand totals. So by doing that we get our total on the right side, and with that we get a perfect waterfall chart in Tableau. Now we have the Pareto chart. It is a very famous chart in the statistics, and this chart is based on the Pareto principle, where it used the rule of 80-20. And the principle says 80% of the outcomes are generated from 20% of work or efforts. And one way to visualize the Pareto chart, we can use two different charts. The first one gonna be the bar chart and the second gonna be the line charts. So let's see how we can build that in Tableau. First, we're gonna start with the dimension subcategory. So drag and drop it to the columns. And then we need our measure. Let's check the sales. So drag and drop the sales to the rows. And now in order to have the Pareto effect, we have to sort the data descending. So first should comes the data with the highest sales, and then we go descending to the right side. So what we're gonna do, we're gonna go to the sales over here and sort it. Perfect. Now we have the bar chart. The next step we want to do is to build the line charts. So in order to do that, we're gonna go and get the sum of sales and duplicate it. So hold Control and duplicate this field. And with that, we got our two charts. So since the second chart gonna be a line chart, let's go and switch it. So I'm gonna switch the sum of sales, the second one, and instead of automatic, we're gonna have it as a line. And as well, I'm gonna change the color to orange. Perfect. As usual, we have to go and merge those two charts together. So let's go to the sum of sales, right click on it and dual axis. And here our chart is broken because the first chart is automatic. So let's go to the first one over here and switch it back to bars. Alright, so we are not there yet because we have to work on the line. The line should be the percentage of the running total. So in order to do that in Tableau, it's really easy. Let's go to the sum of sales over here, right click on it, and let's go and add a table calculation. Alright, so now we're gonna go and configure our table calculations for the second measure, and as I said, here we have to do two things. First, we have to calculate the running total, and then we have to apply the percentage. So in order to do that, let's go and change the calculation type to a running total. So let's go and select that. And with that, as you can see in the background, we have a running total, but the principle here is based on the percentage of the running total. So we have to go and switch this to a percentage. In order to do that, we're gonna click over here and say add a second calculation. So let's click on that. So with that, we get a primary and secondary calculations. The first one can be executed as a running total, and then on top of that, we want to get the percentage. So let's go and switch it from difference from in the secondary to percent of total. Let's click on that, and that's it for the table calculations. Let's go and close it. And with that, we have built our Pareto charts, but let's understand what is going on over here. So now in order to easily read this, I'm gonna go to the second one, to the line, and let's put the labels on top of it. And of course, the principle says 80-20. That means 20% of those subcategories should cover the 80%. And as you can see, we cannot say that in this business. So if you check our subcategories in this example, you can see it's not 20%. We have around 9 subcategories in order to reach the 80%. So in this example, our business does not follow this principle. It's not 80% of the sales are covered by 20% of the subcategories. Alright, so this is one method on how to create Pareto chart in Tableau, and this is how you can read it. Alright, so now we're gonna learn another method on how to create Pareto chart in Tableau. This time we're gonna go and use two different measures using only one line. So let's see how we can do that. Now we have the business question, and it's asked us, do the 20% of the products makes up 80% of the sales? So now let's go and get the answer from the data. In order to do that, let's get first our first measure. It's gonna be the sum of sales. Drag and drop it to the rows. And now let's go and get our second measure. It's gonna be the count of products. So in order to do that, let's take for example the product name to the columns. And Tableau asks us here, we have a lot of members, so add all members. So now as you can see, we have a dimension, but we want to count how many products we have inside our data. So right click on it and let's go to the measure, and then let's select count distinct. So with that, we got our two measures. One more thing that we need inside the details in order to do the calculations, we need as well the product name to be on the details in order to use it. Alright, so I'm gonna go over here and switch it to entire view. So let's go to the first measure, right click on it, and let's add table calculation. So here again, we have the same stuff. We're gonna switch it to a running total, and then we're gonna go and add a secondary calculation. The secondary calculation is going to be the percent of total, and as well let's specify the dimension. So let's go and specify the dimension to the product name. The same as well for the right side, it's going to be the product name. Alright, so with that we got everything ready for the first calculation. Let's go and close it. And now as you can see, we have already now the percent of the running total for the products. Let's do the same stuff for the sales. So right click on the sales, And then let's go and add table calculation. Let's go to running total, specify the dimension, gonna be the product name, and let's go and add the secondary calculation. It's gonna be the percent of total. And then the same stuff, we have to go to the specific dimension and specify the product name. Alright, so with that we have prepared everything for the second calculation. Let's go and close it. Now we have to go and switch it back to line since we have it as automatic. So Tableau he decide to go with the shapes. So let's go and switch it to line. And now with that we are almost there. We have the running total of both of the measures and we have our line. But as you can see, the line is a little bit jittery, and that's because we haven't sorted the data yet. It's very important for the Pareto charts that we sort the data like we have done in the method 1. So now let's go and sort the product name by their sales. In order to do that, right click over here and go to sort, and then we're gonna sort it by the sales. So let's switch it to a field and let's go and select the sales from the field name over here, convert it. So let's make it as a descending. Perfect. Now we got exactly the Pareto chart that we need. So now we have to check whether it's true that 20% of our products make up 80% of our sales. So now in order to check that quickly and easily in the view, we can add the support of the reference lines. So let's go and add some reference lines. Let's go to the analytics over here. Let's take here a reference line. Let's drag and drop it first to the first value. And now what we can do, instead of having the average, let's go and switch it to constants. And now here we're going to check whether the 20%, so it's going to be 0.2. And now with that we're gonna get a reference line exactly on the 20% of the products. Let's go and close that. So with that, as you can see, we have a very nice line, indicates exactly the 20% on the products. The next step is that we're gonna go and add another reference line for the sales. So let's take a reference line, drag and drop it exactly on top of the sum of sales. And now we're gonna do the same stuff. Instead of average, let's switch it to a constant. And since we need 80%, it's gonna be 0.8. So with that, we got exactly the 80% of the sales. So perfect. Now we have our Pareto chart and we can easily answer these questions from our data. So we can say, yes, 20% of our products are covering 80% of the sales, which is exactly matches the rule of 80-20, the principle of the Pareto. Alright, so this is the two methods on how to create Pareto charts in Tableau and analyze your business. Alright, now we have the butterfly chart, or we call it sometimes the tornado charts. It is a great chart in order to analyze two different measures by specific dimension. So for example, if you want to compare the number of customers with the number of orders by the category, then the butterfly chart is your chart. So what do we need first? The dimension. It's gonna be as usual the subcategory. Let's move it to the rows, and then as usual I'm gonna move it as entire view. Then we need our two measures. The first one is gonna be the customer count. Let's move it to the columns. Then the second one gonna be the order count. Alright, so with that we have our two measures and the subcategory. Now in order to form the shape of the butterfly, we have to have the dimension exactly in the middle, and then on the right side we have one measure, and on the left side we can have another measure. So in order to do that, we're gonna use the placeholder, the average of 0. So let's have it over here, and let's go and place it exactly in the middle. So now with that we have the measure on the left, measure on the right, and something empty in the middle. And then let's go and configure this chart. It's going to be the middle one, the average of 0, and let's go and switch it to a text. And now the next thing, we have to go and get the dimension to the text over here. And with that, you can see we got now the spine of the butterfly. So let's go and make it a little bit more bold. So I'm going to go over here and just make it bold. But now we have to have the two wings, right? On the right and on the left. You can see the right side is okay. So we have it as a wing. Let's go and sort the data, by the way. But the left wing is not correct yet. So in order to do that, let's go to the count of customers over here on the axis. Let's edit the axis. And let's go and reverse the scale. So with that, we get exactly the opposite in the scale. Let's go and close it. And as you can see now, we got it perfect. On the left side, the wing of the customers, and on the right side, we have the orders. So now the next step is what we usually do is to add some coloring. For example, let's stay at the customers over here and drag, holding control, the count of customers to the colors. And as well, we can go to the orders over here and drag and drop the orders by holding control to the colors. But of course, we can go and customize the right side with using different coloring. So let's go to the colors over here and change the pattern maybe to orange. Let's hit OK. And as well, we can go and make the text in the middle a little bit more bigger. So let's go to the middle, and then let's make it maybe something like 15. And now we can see those subcategories in the middle very clearly, but since we have it in the middle, we don't need it on the left side, right? So let's go and hide it, right click on it, and then let's go and disable show header. And as well, we can go to the axis over here and as well disable the headers. And of course, we can add more formatting in order to remove those grids. So right click over here on the empty space to the format. And then we can go to the columns tab and as well remove the grid line. And with that, we got a clean chart represent a butterfly or a tornado, depending on how you see it, where you can go and compare two different measures by specific dimension. Alright, so now in the method 2, we're going to bring those two wings together. In order to do that, we're going to get exactly the same information. Let's go and get the subcategories to the rows. And then as usual, switch it to entire view. Let's go and get our measures. So the first one gonna be the count of customers. And then the second one gonna be the count of orders, but we have to put it now on top of each others. And since we are using the same type of charts, we're going to use the measure names and measure values. So take the order counts and drag and drop it on top of the axis over here in order to generate the measure names and values. All right, so we have those informations. Now we're going to go and take the measure names. We don't need it on the rows, so drag and drop it to the colors over here. And just to make sure that everything stays as bars, I'm going to go from here and switch it from automatic to bar. And now the next step, we're going to go and sort the data. So click on the axis over here and then sort the data descending. Both of the values or the wings are on the right side. So now in order to have the effect of left and right, we don't have here two axes. What we're going to do, we're going to do a very small trick. In order to do that, let's go to the customers over here, double click on it and just go to the front before the counts and put a minus. So let's go and hit enter. So with that, we get again the effect of the butterfly where we have the left and the right wings together. But of course, what is missing here is the spine, the dimension, the subcategory. So in order to do that, we're going to do the same. So we're going to go and have the average of 0 as a placeholder. We have it now on the right side. So let's go switch to it. And then we can switch it to a text since we want to have a text of the subcategory. And then the next step, we're going to go and get the text. So it's going to come from the subcategory, drag and drop it on top of the text. And with that, we got the values or the spine of the butterfly. So the next step is that we're going to go and merge them together in one chart. So what we're going to do, we're going to go and use the dual axis, right click on the average, and then here we use the dual axis. But as you can see, those values are not yet in the middle, and that's because we haven't synchronized the axis. So go to the average over here, and then let's select synchronize axis. And with that, we got the spine exactly in the middle, but it's not really clear because it's red. So let's go and change those colors. So let's go to the average over here, double click on it, and let's select complete white. So that's it, click OK. And now the next step, as usual, we're gonna go and start hiding stuff because all those informations are not necessary. So the average over here, let's go and hide it. And as well, we don't need the header informations because we have it already in the middle. So right click over here and disable show header. And with that, we get a very elegant and nice butterfly charts in Tableau where both of the wings together. And now you can go and analyze the coloration between the number of orders and the number of customers by the category. Alright, so this is how you can create butterfly or tornado charts in Tableau using two methods. Alright, so now we're gonna go and learn how to build quadrant charts in Tableau. This type of chart is gonna go and present a lot of data points in one view using two measures, and then we go and compare those different data points based on their position on the quadrant. And then we go and split the chart into 4 different quadrants. This type of chart is really great in order to do strategic planning or to do risk management or as well to find some trends. So now let's go and check in Tableau how we can build that. So the first thing that we need is two different measures. The first one gonna be, let's take the discount and put it on the columns, and then let's go and find the average of the discount. So right click on it and let's go to the average instead of sum. So this is our first measure. Now we need another measure, and this time gonna be the profit ratio. We don't have it in our data, so let's go and quickly create it. So create a new calculated field, profit ratio, and it's very simple. So it's gonna be the sum of profit divided by the sum of sales. So that's it. Let's go and hit OK. And then let's go and bring it to our rows. So with that, we got our 2-axis, but I would like to have it as percentage. So let's go and change the formats. Let's go first to the profit ratio. And then instead of numbers, let's go and switch it to percentage. And then let's go and remove those decimals. The same thing, let's do it for the average of discounts. So let's go and format it as well to percentage and remove those decimals. Alright, so that's all for the axis. What do we need now is the customers as a data point. So in order to do that, let's go and get the customer ID and let's put it on the details. So now as you can see, each of our customers are presented as a data point. Let's go and change the visual of that. Instead of shapes, let's have circles, and let's go and reduce the opacity in order to see the overlapping between those points. And as well, we can go and make it a little bit bigger. So now we need 2 values in order to split this chart into 4 different quadrants. And now here, since we have the title as dynamic, we want to offer it to the users as parameters in order to specify those 2 values. So now let's go and create 2 parameters in the data pane. So we're going to create the first one. Let's say select discount. So it's gonna stay as float and the display gonna be as a percentage. Let's reduce the decimals, and then let's say that the default is gonna be 0.15. So with that, we're gonna get 15%. So that's it for the first one. We're gonna do exactly the same for the second one in order to get the profit ratio. So let's create another parameter and we're gonna call it select profit ratio. We're gonna have the same stuff again, so we're gonna have it as percentage, reduce the decimals, and let's have it as a 10%, so 0.1. So that's it for this one. Let's go and close it and show it in our view. So show parameter and show parameter. Now we have it on the right side. Next we have to create now a separation in our view in order to show how the data are splitted. So in order to do that, we're gonna add 2 reference lines. So let's start with the profit ratio. Right click on it and add a reference line, and then the value gonna depend of course on our new parameters. So select profit ratio, and then let's go and make the label empty, and then we can go and change the format. Instead of having a line, let's have a dashed one, and then let's have it black, and then increase the opacity, and that's it. Let's hit OK and do the same as well for the discount. So right click on the discount, add the reference line. We need our parameter. It's gonna be select discounts. Remove the label and as well do the same stuff on the customization. So we're gonna have it as dashed and as well have it clear on our view. Alright, so now let's go and hit OK. Alright, so now as you can see, we have already our quadrant charts where we have splitted our data into 4 different sections. And of course, we can go now and change those splitters using the parameters. So let's go to the profit ratio and change it to 0.2. So with that, we move it to 20%. Now, of course, what is missing in our quadrant is the colorings of those points. So each section should have its own colors. And in order to do that, we have to go and create another calculated field to have those 4 values. So let's go and create one. So let's call it quadrant color. So now we have to go and identify the position of each data point inside our quadrants. So let me just move it a little bit over here. And in order to do that, we can use the if else statements. So let's start first identifying the points on the upper right. So all those points on the upper right. So how we're going to do it? We're going to say if the profit ratio to the parameter value that is selected from the users. So we're going to say select and then the profit ratio. So that means we are checking whether the user on the upper section, and now we have to check whether it's on the left or on the right. So we're going to talk about now the discount and the average discounts as well, higher or equal to the value selected from the parameter. So we're going to write select and discounts. So now we are targeting all the customers on the upper right. So what's going to happen if the condition is fulfilled? We're going to say upper right. Alright, so now we're going to go and do the same stuff for all other 3 sections. So let's go and just copy it from here. And then we're going to say else if. And then let's go and paste it. Let me just make it a little bit bigger in order to see it. So now what we're going to do, we're going to go and target the upper left. So in order to do that, we have to go and change the discount to smaller. So now we are saying if the discount is smaller than the selected value in the middle, so that means we are on the left side. So what's gonna happen, we will just go and flag it with the following value, upper left. Then we have to do the same stuff for, let's say, so now we're gonna go and target the bottom right. So let's call it bottom right. For the discount part, it is not correct. So let's move it like this in order to have the right section. And for the ratio, in order to be in the bottom, this time it's gonna be smaller. So with that, we are at the right side. And for the last section, in order to target it, we don't have to go and specify it. We will say just simply else. Because if none of those conditions are fulfilled, we will end up by the last one. So we're gonna call it bottom left. Okay, so that's all. Let's go and end our if else statements, and the calculation is valid. Let's go and hit OK. And with that, we got our new calculated field. Let's go and drag and drop it to the colors. So now, as you can see, we have a dedicated color for each different sections inside our quadrants. And of course, if the users goes over here and change the values of the parameters, the coloring will react as well, since we have the parameters inside our calculated field. So for example, instead of 15, let's have it as 0.25. So now, as you can see, the reference lines goes to the right side to the 25%, and as well the coloring will be adjusted. So that's all. This is how you can create a very nice dynamic quadrant chart in Tableau. Now we're going to talk about the box plot in Tableau, or sometimes we call it box and whisker plot. This type of chart going to help you to understand the data distributions of your data sets. So this chart has like a box and two whiskers on the top and on the bottom, and then in the middle we have the median and the edges of the box. So with that, we will get 5 different numbers in how our data is distributed. So let's see how we're going to build that in Tableau. It's really easy. So let's start as usual with the sales. Let's drag and drop it to the rows, and then we're gonna see how the sub of categories are distributed on those sales. So let's take the subcategory to the details first, and then we have to change the visual to circles. So let's go to the marks over here and change it to circles. So now, in order to have different charts, I would like to add the category to the columns over here, and then let's go and make it a little bit bigger to the middle over here. And now let's go and reduce those circles a little bit in order to have it more clear. And with that, we have the first part of the box plots where we have circles. Next, we have to get those numbers or the shape of the box and the whiskers. In order to do that, we have to add a reference line. So let's go to the sales over here, right click on it and add a reference line. And here everything is prepared from Tableau. If you go to the box plot over here, and that's it, let's click OK. And that's it actually. With that, we got a box plot in Tableau. So now if you go and mouse hover on the chart, you will get the 5 different values: the upper whisker, the lower whisker, the median, and so on. Alright, so now the question is how to read the box plots. Well, there are a lot of information over here, but the first thing that you can do is to compare the position of the median of each box. So if you have a look over here, you can see that those two boxes are at the same level, right? So they are very similar categories. But if you check the office supply, that you can see the median or the box itself, it is below those two other boxes. This can indicate for us that the furniture and technology has a same distribution, but the office supply has a different one. And another thing that you can check is the size of the box itself. If the box is tall or the length of the box is long, then that means the subcategories inside this category are not really similar and they are far away from each others. But if you check the office supply, you can see that the box is shorter, so the length of this box is smaller compared to the other two. That's gonna give us the information or the hint that the subcategories of this category, the office supplies, has like a similar sales. So that means if we have a shorter box, the members of this category gonna have a similar behavior. But if you have a tall box, that's gonna suggest that the members of those informations gonna have different sales. But if we have a big or tall box, that means the members of this category gonna have different behavior. And of course, this type of chart gonna help us to find the outliers, especially on the upper and on the lower whiskers. Alright, so that's all about the box plot in Tableau. Okay, so now we're going to talk about the KPI charts, key performance indicator. We usually use it in order to analyze the performance of our business, whether it is succeeding or failing. Alright, so now let's go and build a KPI in order to track the performance of our sales in our business. So let's go and do that. As usual, we're going to go and get the subcategories to the rows. Let's take the sales as well to see the numbers. And then the next step, let's say that we want to check the sum of sales for each country. So let's go and grab the country field to the columns. And then the next step, we have to define the core of the KPI, the rule. When the sale is going to be considered as a success and when it's going to be considered as fail, or maybe in between. So what we have to do is now to go and create a new calculated field in order to define the KPI rule. So now let's go and call it KPI colors. So now by checking the data, let's say that if the sum of sales is higher than 50k, then it's going to be considered as a success. Or if we are talking about colors, it's going to be green. We're going to work with the if else statements. So we're going to check whether the sum of sales is higher than 50,000. Then what's going to happen? We're going to say it's green. So now the next step, we have to define the second rule. Let's say that if the sales is between 10k and 50k, this is gonna be medium, or let's say orange. So let's go and build that using else if the sum of sales less or equal 50k and the sum of sales, we are making like a range, is higher than 10k. Let me just make it a little bit bigger. Then what's gonna happen? It's gonna be orange. Alright, then we have the third rule. If it's not in between or not higher than 50,000, then it's going to be less or equal to 10k. So what we're going to do at the end, we're going to say else it's going to be red. So that's it, let's end it. So this is our KPI rule in order to track the performance of the sales. So let's go and hit OK. And with that, we got a dimension here on the left side, the KPI colors. Let's go and grab it and put it on the colors. So now the next step, let's go and assign the correct color. Tableau got it almost correct. So let's edit the colors. The orange is orange, red is red, but the green is blue. So let's go and switch to that. And with that, we can immediately track the performance of the sales, where we can see immediately where we are performing good. So you can see those green numbers, or we are performing bad by the red numbers. But if you saw any KPI dashboard, you will see that they are using a lot of shapes. So now instead of those numbers, let's go and get shapes assigned to those three values. So that means we're going to go to the marks over here and switch it to shapes. Now things are ugly currently, so let's go and take the sum of sales to the details. And then we're going to take the KPI color to define the shape of our visual. So with that, we got different shapes for each level of our KPI, but I would like to change it. So let's go to the shapes over here. And then let's go to the default and then switch it to KPI. So now we have better icons for our KPI. Let's go and switch stuff. So green, it's going to be this icon. Orange, it's going to be this. And then the red, it's going to be the red one. All right, so that's it. Let's go and hit OK. And now we can go over here and make it entire view. And as well change the size of our KPI. And with that, we got a nice KPI where we can see immediately where we are doing good and where we are doing bad. So this is how we can create KPI in Tableau. Alright, so now we're going to learn how to combine a KPI together with any other type of charts, like for example, the bar charts. So now we're going to go and build view in order to compare 2 years. In order to do that, we're going to get the same stuff. So let's get the subcategories to the rows. And then here we have the sales of 2022. Move it to the columns over here. So with that, we got our bar chart, but I would like to move it from automatic to bar in order to make everything stable and not later break in our visualization. So the next step, I would like to go and add as well the coloring. So let's take the sum of sales 22 and put it in the colors. And now the next step, let's take the 2021 as a reference inside our view. So let's move it to details and then let's go to the axis, right click on it and let's add a reference line. So here we would like to have the value of 2021 for each category. So let's switch it to per cell and then select the 2021 and then let's go and hide the labels. This is only customizations. Then let's move it to a little bit heavier line and then increase the opacity and as well change it to orange. So that's it. Let's go and hit OK. So now in order to see the data better, let's switch it from standard to entire view. And with that, we got a reference from the previous year and the bars are the current year. So with that, you can see quickly the differences between the 2 years, but we are not done yet. This is only the bar charts. Now we have to go and add a KPI for it. So here we have to define the rule of the KPI and this time it's going to be easy. If the current year is less than the previous year, then it's going to be red. If it is more or equal, it's going to be green. So let's go and define this rule. As usual, we're going to go and create a new calculated field. We're going to call it KPI colors. So now we're going to go and define the rule. We're going to use as well the if else statement. So if the sum of sales of 2021 is higher or equal to the sum of sales of 2021, then we are safe. It's gonna be green. Let me just make it a little bit bigger in order to see everything. But if the condition is not fulfilled, what's gonna happen? We will have bad performance. So it's gonna be else, red, and then ends. So this is our rule. Let's go and hit OK. So now for the KPI, we need another chart inside this view, but since it is like a dimension, if we bring it to the view, it will not split it to two different visuals. So in order to generate another chart, we will use the trick of using the average of 0. So we have to create a placeholder, average of 0, and with that, as you can see, we will get a new chart on the right side. So in this measure, we will go and configure our KPI. Let's go and switch to this marks, and now we're going to switch it from bars to shapes. It's like we are building any other KPI, and I will go and get rid of those informations. And now we're going to go and get our new calculated field, the KPI rule, and put it on the shapes. And next we're going to go and define the shapes of our KPI. So let's click on shapes, and let's say if it's green, then it's going to go up, and if it's red, it's going to go down. That's it for the shapes. Click OK. And as well, we want to change the coloring of those stuff. So let's take the KPI colors, hold control and put it on the colors, and let's go and assign it. So edit colors, green gonna be green and red gonna be red. So that's it. Click OK. So now we have our KPI on the right side. So we can go and make it a little bit bigger in order to see the shapes. So now we have two different charts. The next step, we're gonna go and use the dual axis, and that's because they have different shapes. So let's go to the right side and have the dual axis, and as usual, we're going to go and synchronize the axis and remove one of them. Let's go to the average as well, and then go and disable show header. With that, we hide it. So with us, we got the two KPIs on top of each others, but still here we have an issue. As you can see, the icons of the KPIs are exactly on the top of the edge of the bars. And that's because everything is starting from 0, and we have here the average of 0. So now what we're going to do, we're going to move it a little bit to the left side using the negative values. So let's go to the average of 0 and switch it from 0 to minus 10k. So with that, we can see our KPI is perfectly on the left side of the bars, and we can see immediately where we are doing bad. So here we can see that almost all of the subcategories are doing great. So we have all those green icons, but only two, the envelopes and the machines, are doing bad. And that's because the sales of the current year is less than the sales of the previous year. So with that, we have learned how to combine the KPI charts with any other chart. It should not be a bar chart. It could be an area or a line chart. Okay, so now we're going to create bands in Tableau. They are those big numbers that you can see usually in KPIs or in dashboards, where you're gonna see the total of something, like the total of sales, the totals of profit, how many customers do we have inside our datasets. So it's very common, and you can see it almost in each dashboard. So let's go and create it. So what we're gonna do first, we have to go and switch our visual from automatic to a text. Since we are working with text, there is no charts or any visuals. So let's take the sales and put it on the text. So now with that, we got one number without any charts, only one big number, the total sales of our data. Now we can go and split it by a dimension like a country. So let's take the country, put it in the columns. So now we can see the total sales of each country. So now, since we are talking about bands, those numbers should be really big. So in order to change that, let's go to the text over here, click on those 3 points, and then let's go to the sales and make it really big. So we're gonna go to the size over here. Let's take, for example, 22 and make it bold. And then you can check by hitting apply the size of those numbers. They looks good. So now let's go and hit OK, and let's make the alignment correct. So let's have everything centered. So on the horizontal and the vertical. So now the next step, we can go and change the format of those numbers. So let's go to the sum of sales over here and go to format. And then we're going to go to the numbers over here in order to change the format. Let's go for custom. So there is no decimal places. Let's make it 0. And then let's say we're going to display the unit as 1,000, as a K. And then we can add the $sign on the prefix over here. So let's go and do that. So that's all about the format. Let's go and close it from here. And now with that, we have created really nice bands for our dashboards. We can go and make it a little bit bigger in order to see those numbers. And now you might say, you know what, I would like to have those texts beneath the numbers, not on top of it. So in order to do that, what we're gonna do, we're gonna take the country again and let's put it to the text. And with that, we're gonna get the text below it, but of course we have to make it really small. So let's go to the text over here, then to the 3 points, and then let's go to the country, remove the bold, and let's move it, for example, like 12. All right, so now let's go and hit apply in order to check the format. So now as you can see, we got those small text beneath those numbers, but we can go and as well reduce it to 10 to make it really small beneath those big numbers. So now let's go and hit OK, and with that we got really nice small text below our numbers. But we still have an issue where we have the header informations. In order to remove it, just go to any values like Germany over here, right click on it and disable the show header. And with that we got a really nice pans where the text is below the big numbers. So as you can see here, we didn't use any type of charts, we just used the text in Tableau. Now we're gonna learn how to build a funnel chart in Tableau. Funnel charts are really great in order to show the progress of your data through different stages. So let's see how we can build that. Let's take the sales and put it in the rows. And now we want to see how the sales are progressing through the different subcategories. So let's take the subcategories from the products and put it to the colors. Now the next step, we would like to change the size of those blocks based on the sum of sales. So in order to do that, let's take the sum of sales by holding Control and put it to the size. And now let's go and switch it from standard to entire view in order to see the size of each block. And now we need to form the shape of the funnel. In order to do that, we're gonna go and sort the data descending. So the biggest one gonna be on top and then we go to the small. So in order to do that, let's go to the subcategory over here, right click on it and let's go and sort it. And then we have to change the sort by to a field, then move it to descending, and that's it. As you can see from the background, we have now the shape of the funnel. So now the next and as well the important step in the funnel chart, we want to show the percentage of total for each block. So in order to do that, let's take as well the sum of sales and put it to the text. And with that we got the total sales for each subcategory, but we don't want that, we want the percent of total. In order to do that, right click on it and let's go to quick table calculations. And then let's pick the percent of total. Great, so now we have those percentages on the funnels, which is very nice in the funnel charts. Let's go and add as well the text of the subcategory. So let's take the subcategory and put it to the labels. So now we can go and customize our view a little bit where we say, okay, let's put the text of the subcategory on top of the sales. So switch the order and then let's go and change the labels and make the subcategory a little bit bigger and bold. So let's hit OK. And as well, we can go and remove those grid lines. So right click over here to the formats. Let's go to the lines and then let's go to the zeros over here and make it none. Alright, so that is more clean. What we can do, we can add the category to the filter. So let's go to the category, show it as a filter. And with that, we can go and select specific category in order to see the data. So with that, we get like less blocks inside the funnel chart, or you can go and add all of them. So that's it. This is how you can create funnel chart in Tableau in order to track and check the progress of your data. In our KPI dashboards, we can add stuff like a progress bar. Let's see how we can build that in Tableau. So now let's go and get a dimension like the country to the rows. And then we're gonna go and track the progress of our sales as a progress bar. So in each progress bar, you have like 2 bars. The one in the background for the 100% and then your actual progress. So that means we need 2 bar charts. Let's stick with the first one and switch it to bar, and as well, let's show the text. But now instead of the total sales, let's go and switch it to a percent of total. So let's go and switch our sales to a quick table calculations to a percent of total. Alright, so on the next step, we want to add the background color. So what we're gonna do, we're gonna add our placeholder average 0. So now the next step, we're gonna go and add the background bar. So in order to do that, let's go and add our placeholder. It's gonna be the 1, average of 1. So now we got our background on the right side, and on the left side, we're gonna get the actual progress. Let's go and merge them together using the dual axis. So right click on the right one and then move it to dual axis. Okay, so as usual, we're going to go and synchronize those two axes, and let's go and make it a little bit bigger in order to see the bars. So now we can see that the average, the background is in the front. In order to switch that, let's go to the axis of the average, right click on it, and then here we can say move marks to the back. Alright, so now the next step, in order to get the effect of the progress bar, we have to change the coloring of the background. So let's go to the colors, edit, and then let's select the average and let's take the blue. Let's select something lighter, so let's take a light blue, apply, okay. Alright, so with this we get the effect of the progress bar. Let's go and hide a few stuff, like for example this X over here, and as well let's hide those numbers on the background. So let's go to the labels and hide them. Alright, so that's it. This is how you can create a really nice progress bar in Tableau where you can put it inside your dashboards. Alright, so we learned how to build 63 charts in Tableau and what are their use cases, but you might be still like overwhelmed with all those options and all those charts in Tableau. And it's still not that clear how to answer the question, how do we know which chart, which visualizations that we have to pick? So that's why we're gonna go now and summarize and group all those charts under different categories. So we have the change over time, magnitude, part to whole, colorations, ranking, distribution, spatial, and flow. And each of those categories is gonna focus on a specific question, a specific problem, in order to answer it using visualizations. So now let's go through all those categories one by one in order to understand them. Alright, so now we're gonna start with the first one and the most basic category. We have the change over time, or sometimes we call it trends over time. So this category gonna show us the trends or the patterns over a continuous period. And it usually answers the question, how does the data change over time? Or another one, are there any trends or patterns that we can uncover from the data over time? So if you have this kind of questions, then you are talking about the category change over time. And the best chart in the category, we have the line charts, because the line charts focus only on one thing, the changes over time, the trends over time. Because mainly the line charts focus only on the changes over time, the trends over time, nothing else. And as well, visually, it makes it really easy to spot trends. And as we learned before, we have multiple charts that covers the topic of change over time. Of course, all the line charts usually are change over time. So we have the line chart as the perfect one. Then we have as well the spark line charts. We can use it if you want to have a compact chart for the trends analysis over the time, or we can use the sloppy chart to see how the ranks is changing over time, or as well we can use a bar chart. So we can use the bars as well in order to analyze the changes over time, and as well to go and compare different time period together. And not only the bar charts, we can use any type of area charts, for example the stacked area chart. Here we have different use cases. One of them is the change over time, and as well to go and compare different categories together. And as well we can go and use the calendar chart or the circle bubble timeline in order to visual the change over time. So as you can see, if you want to have only one use case inside your visualization to show the change or the trend over time, then go with the line charts. If you want to go and cover multiple use cases in one chart, then you can go and use the area chart, bar chart, or the circle time charts, because they don't focus on only one use case. They can cover multiple use cases, and one of them is the change over time. Alright, so now we have the magnitude category, or sometimes we call it size category, and it uses the size in order to compare values. So we could use relative or absolute values in this category. So for example, if you have the following task or question, find out the highest and the lowest sales of the categories, or we have to go and compare the different categories by sales in one chart. So if you have such questions or tasks, then we are talking about the category magnitude, and the best chart for this question is the bar chart, because it makes it very easily and clean in the visualizations in order to compare values. You can compare very easily the data by comparing the length of the bars of each category. And under this category, we can find multiple charts, and most of them are bar charts. So we can use the row bar chart as a main one, or we can use a bar chart columns. As we learned before, if you have a dimension with high cardinality, you can go with the row, but if you have a chart with a low cardinality, then go with the column. So those two charts only cover one dimension, but if you have multiple dimensions, then you can go with the side by side bars or the stacked bar charts, or as well the full stacked bar charts. Then we have different charts under this category like the lollipop charts, bubble charts, and the scatter plots. And you might ask why scatter plot and why bubble chart? Because the size of the bubble gonna be used in these analyses. So we can see immediately that the technology and the furniture has the highest sales from the size of the bubble. The same thing goes for the scatter plots. So here again, it really depends on how many questions you want to cover in one visualizations. If it's only one use case to go and compare the data, then go with the row bar chart or the column bar chart. But if the size comparison is not only the use case that you want to cover multiple stuff like adding multiple dimensions and measures, then you can go with the other charts under this category. Alright, now we have the category bar to whole. It shows how a whole or a value breaks down into its components and how each component's gonna contribute to the whole, to the total. And it's gonna show how each component gonna contribute to the whole, to the total. So if you have a question like how does the value contribute to the total, then we are talking about bar to whole category. And the best chart to visual the answer is the pie chart, because visually it's very easy and as well very effective to show how each slice of the pie gonna contribute to the whole pie. And in this category, the bar to whole, we have different chart types. Like as we said, the main one is the pie chart, but we can go and use the donut chart, especially if you want to show the information of the whole, the total. So you can present it in the middle and around it, you're gonna have the slices. Or we can go and use the bar chart, for example, the full stacked bar chart or the area charts, the full stacked area charts. And as well, you can go to the tree map if you want to analyze not only the bar to whole, but as well you want to show the hierarchical data. And as well, we can go to the waterfall in order to show part to whole and as well the flow of the data. So here again, if you want to only focus on the part to whole use case, go with the pie chart. But if you want to add more information and analyze different use cases, then you can go with the others. Alright, now we're going to talk about very important category. We have the correlations. It's going to show the relationship between two or more measures in one visualization. So this category is going to answer questions like, is there any relationship between two measures? Or how strongly related are two variables or two measures? So if you have such a questions, then we are talking about the category correlation. And the best chart in order to visual the correlation is the scatter plot. The scatter plot is very effective in order to show the relationship between two measures. And it covers a lot of use cases like discovering the outliers. It's very flexible. We can add a lot of informations to each data point, and as well it's going to help us to build clusters. So if the question to show the relationship between two measures, the best chart is to use the scatter plot. And underneath this category we can find different type of charts, not only the scatter plot, but scatter plot is the favorite one. So we have the quadrant chart. We can use it as well to analyze two measures and as well to cluster our data or to split it to 4 sections. Or we can go and use the dual line chart if you want to see as well the changes over time, not only the coloration, but you can see the trends as well. So we can go and use 2 lines in order to analyze the coloration between 2 measures, or we can go and use 1 line and 1 bar chart coloration, and as well we can go and compare the sizes of each bar. Moving on to another chart which is very beautiful in order to go and compare 2 measures, we can use the butterfly or tornado chart. And the last one, you can use as well the histogram in order to find the coloration between 2 charts and as well to show the distribution of your data. So again, if you want only to focus on the correlation, nothing else, you can go and use the scatter plots. But if you want to go and add different use cases like the change over time or the distribution or comparing the sizes, then you can go and use the other ones. Moving on, we have another category called ranking. So we use this category if the most important thing to show is the position of the item in a sorted list. So for example, if you want to show the ranking of customers, the top 10 customers by the sales or the lowest 10 products by the sales, then we can use the ranking category in order to solve those tasks. And the best charts in this category is the bar charts, because bar charts are really amazing in order to build a list and as well to go and compare different ranks together. Alright, so in order to show the ranking, we have different types of charts. The basic one, as we saw, we have the bar chart, whether it's row or columns. And then we have different charts if you want to add more informations or more use cases in one chart. For example, the lollipop chart, where you can go and put 1 extra information inside the circles, or you can use the sloppy charts. So here not only we are seeing the ranks between countries, but we can see how they are changing over time. And we have other charts like the funnel chart or the pump charts as well. Here we can show the ranks, how they are changing over the time. And the last one, we can use as well the butterfly in order to show the ranking of the categories, for example here, and as well the correlation between two measures. So here again, as usual, if you want to focus only on ranking, only on this, you can go and use the bar charts. But if you want to go and cover multiple use cases in one visual, then you can go and use the other charts. Alright, so now we have the distribution category. We can use it in order to show the values of a datasets and the frequency of their occurrence. So if you have the following question like, what is the distribution of customers' age? Or if the question is, what is the busiest time in the workday? So if you have such a type of questions, then we are talking about the distribution category, and the best chart to visual those questions and the answers is to use the histogram. Histograms are an amazing way in order to show the patterns using pens, and it's going to make it very easy to understand the distribution of the data. Under the distribution category, we can find different types of charts. The main one can be the histogram, and we can go and use different type of plots like the box plots in order to see the distribution of data as well for the dot plot over the time. And as well, we can go and use the scatter plots or the quadrant chart in order to see the distribution of our data, and as well to show the correlation between two measures. We can go and use as well the barcode charts. For example, here we can see the distribution of each product in each subcategory, and as well the bar chart considered to be a distribution chart. So here again, if you want only to focus on the distribution, then go and use the histogram. But if you want to cover multiple use cases in one view, you can go and use the other charts. Moving on, we have the spatial category. Use it when the geospatial pattern of your data is the most important thing that you want to show. So if you have questions or tasks that involves information about the location like countries, cities, states, like for example, you want to show which city had the highest sales, then we're going to go with this category, the spatial category. And of course here, the charts that you're going to use in this type of visualizations is the map. And in this course, we have built 4 different maps. The first one, the filled map, or we call it choropleth map. So here, as you can see, the states are filled with colors, or we can go and use symbols. Like here we are using the star in order to show the sales for each state. And then we have learned how to customize the maps. For example, here we have created the night vision map. Alright, so now we're going to talk about the last type of category. We have the flow. We're going to use it in order to visual the movements or the flow of our data. So if you have a question like how the data is moving from one point to another point, then we are talking about the category of a flow. And one very common chart in order to show the flow of the data or the process of the data, we can go and use the waterfall charts. So with this chart, you can see the movement of data or the flow of the process of your data. And as well, we can analyze here the part to whole. Alright, so with that, we have covered the 8 different categories, and we mapped different charts that we have learned in this course to those categories. So as you can see, the process is really simple. In order to understand which chart of visualizations you need in your projects, first you have to understand the questions that should be answered. So once you understood the task or the business question, you can go and map it to one of those 8 categories. And after that, you're going to go and choose the best charts within each category in order to answer the question. And with that, you have learned the process of choosing the right visualization, the right chart for the question. And make sure to check the description. I left there a link for the visualization cheat sheet, and as well you will find the Tableau file where I have sorted all those charts under the 8 categories. Alright, so with that we have learned how to choose the right chart for your requirements, and with that we have completed the Tableau chart section. And now in the next section in our plan, we're gonna learn how to create and design our dashboards in Tableau. Tableau dashboard. Now we're going to learn the basic principles about how to structure our chart inside dashboards in Tableau, and we're going to focus on the containers in order to structure our dashboard. So once we build all those beautiful charts, we can go and group them in one place using Tableau dashboards. So let's go. Okay, so if you create a new dashboard, you will get different options on how to customize and design your dashboards. So for example, we usually go and start changing the size of our dashboard of this white space. So in order to do that, if you go to the size on the left side, we have here 3 different options: fixed size, automatic, and range. What I usually do, I go to the fixed size. So here we can go and customize the width and the height. So for example, let's go with the width with 1200 and for the height with 800. And then beneath that, we have a list of all worksheets that we have inside our dashboards. And then here it's really important is the objects that we have in Tableau. So here we have a list of different objects like containers, text, extensions, images, blanks, and so on. Those objects, you're going to use them in order to build up your dashboards in Tableau. And the very important object here, we have the containers in Tableau, and they are really confusing if you are new to this tool. So we will be focusing on how to work with the containers in order to build the structure of our dashboards. So the first question is, what are containers? Containers in Tableau can allow you to group up different Tableau objects together in one place. The object could be anything like a worksheet, blank, text, images, or even another container. So once you have all those different objects in one place, you can do many stuff like, for example, moving them all together using the container from one position to another one. So let's have a quick example. Let's take one of those containers. Let's take the horizontal container and drop it to the middle. And here the first thing to notice is that the coloring in Tableau. So as you can see, we have now a dark blue border around this space. The blue border gonna indicate that this is a container. And now we can go and drop anything inside this container. It could be a worksheet, it could be a text, blank, anything. So let's go with any sheets. For example, I have here one prepared one. So drag and drop it exactly in the middle of the container. So now you might notice that we don't have anymore the blue color, the blue border. We have now a gray border. So that means in Tableau, currently I'm selecting an object that is not container. So now we can go and grab anything, like for example, a text. Let's take this object and drag and drop it on top of this chart. And here let's write anything like the sales dashboards and just make it a little bit bigger. So hit OK. So now with this, you can see we have another object that is contain only a text, and as well it has a gray border. So that means we have one object with gray border and another one with gray border. So now the question is how to select the container that has those two objects. There are many ways in order to do that. So for example, let's say we are selecting the text. If you go over here to those two lines and double click on it. So once we do that, as you can see, now we have again this blue border. That means we are now selecting the whole container. So that means by double clicking on this small icon over here, you are going back to the container that's grouping up those objects. And there is another way in order to select the container. So now let's go again inside it and only click on the sheets over here. So again, we have this gray border. So now if you go to this small arrow over here, we're going to get more options. And then here we have the option of select container, vertical container. So once we do that, we will go back again to the containers where we have those objects inside it. So this is another way on how to select the current container. All right, so now you might ask, you know what, why we are selecting the container? Well, for the following reason. For example, if you are just selecting this chart, you can go over here and you will get different options about the worksheets. So for example, you can show the titles, the filters, the highlights, and you can configure only this worksheet. So those options are only related to this objects. But now if you want to go and configure the whole container, you have to go to the container. So for example, let's go and double click on that. And if you go to the options over here, we will get completely different list of options. And anything that you are selecting here is going to be reflected for all objects inside this container. So for example, in the current container, Tableau can show us there is still space left inside this container in order to fill it. So the whole space over here is not used, which is not really good. And as you can see, we have the text object is way smaller than the worksheet object, which is now fine. But what you can do in Tableau is that you can go and split everything evenly. So if you go to the containers options, you can see over here, distribute content evenly. So if you select that, what's gonna happen, as you can see, Tableau gonna go and automatically split the size of the container evenly for all objects. This is really helpful if you have different charts in one container. So Tableau gonna go and split the space evenly for all objects. So as you can see, the options of the containers can affect all the objects inside the containers. And one more thing to notice in Tableau is that Tableau can create a sneaky container always on the right side. This container is a special one where Tableau can put all the filters, legends, highlighters, and as well parameters always on top of each other's on the right sides. So for example, in the subcategories, we have the filter of the order date, and immediately Tableau can create a special container on the right side and can place the filter inside it. So for example, if you take any other chart that contains those informations, let's take this one over here and put it in the bottom, you will see Tableau immediately gonna go and add the filters inside this worksheet beneath the first one. So here we have the filter of the categories that comes from these charts. And if we take the next one, the customer distributions, as you can see, we will get a lot of filters in Tableau on the right side and as well the legends. So here we have the profit side, here we have the country colors and so on. So all parameters, all legends, all filters gonna be packed on the right side. And of course, if you want to customize the container that Tableau creates on the right side, you can go to any objects and then double click on it, and then you can go and customize it. So for example, I can go over here and split everything evenly. Alright, moving on about the containers in Tableau, we have two different types, the horizontal container and the vertical container. Let's start with the first one, the horizontal container. If you use this type, what's gonna happen? All objects inside your horizontal container gonna be side by side next to each others. So let's try that. Let's take the horizontal container, drag and drop it to our dashboards. And then let's take one sheet, for example, the subcategory over here. And then let's take another one. So once you can select it, as you can see, Tableau can offer you either to put it to the left or to the right. So for example, let's go and drop it to the right. And with that, we got two charts side by side near to each others using the horizontal container. And of course, if we go and add anything, it's going to be as well either to the left or to the right or in the middle. So once you drop it, you will get it as well side by side. So this is how the horizontal containers works in Tableau. Okay, the next tab we have the vertical container. What can happen here? All objects inside this container are going to be on top of each other's like they are stacked. So let's have a quick example. Let's take the vertical container, drop it to the dashboard, and then let's take any charts and as well drop it over here. And now once we select another one, we can put it, for example, below it, and the third one either below, in the middle, or in the top. So let's drop it in the top. So as you can see, the vertical containers, we are putting those objects or those charts on top of each others. So with that, we are stacking the objects on top of each others, and this is how the vertical containers works. One more thing about the type of containers, which is very confusing if you are a starter in Tableau, is that you can decide on the type of container as you are dropping the second object. So let me show you what I mean. Let's take, for example, the horizontal container, drag and drop it to our dashboards. So now we can go and drop different sheets next to each other's, right? So let's take the first one as usual. Let's put it over here. And now we come to the second sheet, and our expectation that we can put it either to the left or to the right because we have horizontal container. Well, the second sheet or the second object is a special one. You can use it in order to change the type of the container. So let's take, for example, this one over here. You can see we can put it left, we can put it right, but as well we can put it on the top or on the bottom. So once I drop it to the bottom, what's gonna happen? Tableau gonna go and convert the type of this container to a vertical container. So now we cannot go and change our mind. It's gonna be fixed. This is gonna be a vertical container. So for example, if I take the third one, I cannot change my mind by putting it to the left or to the right. I can put it only to the top or to the bottom. So it's gonna stay as a vertical, and the third one will not change the container type. So here I can drop it, for example, here in the bottom. On the second sheet, we still have the option to change our mind to make it either horizontal or vertical container. Depends on how you are dropping the sheets. But after that, for the third sheet, you don't have any more of those options. You can drop it, only depends on the container type. Alright, so now the more things that we put inside our container, the things get more complicated in order to control the structure of our dashboards. So there will be a lot of nested containers on top of each others, and you will lose control with the time if you are building a complex container. And for that, Tableau did provide a view of the current structure of our dashboard. So now we are currently at the dashboards. In order to go to the view, let's go to the layout. So let's switch that. And then here at the bottom, we have something called item hierarchy. So here we will see the structure of our dashboard. So it starts with the tilde. So if you click on that, you can see Tableau can go immediately and select the current objects. So here we will see the structure of our dashboard, and it starts with tilde since we are using this methods. So if you click on that, Tableau gonna go and select the current object in the hierarchy. So this is the highest container where we have everything in our dashboard inside it. So let's go and expand our hierarchy. So you can see that it then splits into horizontal container, and that you can see it clearly. We have one container for all those filters, legends, and so on. And on the left side, we have a container for all our worksheet. And you can see that by just like moving this slider over here. So as you can see, the first object is a horizontal container. And then inside the horizontal container, we have two vertical containers. So the first one going to be this container for the chart, and as you can see, things are stacked up on top of each other. So this is our first vertical container, and if you click on the second one, now we are selecting the container on the right side, and it's as well a vertical container. As you can see, all those filters and stuff on top of each others. And then of course we can go and expand those containers to see the content. So as you can see, we have here 3 sheets inside the first container, and in the second one we have 3 filters, and then we have those 2 legends. So having this item hierarchy, it can help us with a lot of stuff. So for example, it can help us to understand the structure of our containers, how things are nested to each others, and another use as well to understand whether we have made any errors by building the containers. So as you are dropping stuff inside your dashboards, weird stuff might happen in Tableau where you are creating way more containers than you need. And it can help us as well to select stuff. For example, if I would like to select the horizontal container, it's going to be a little bit hard here by double clicking on those different objects. It's going to be easier if I go over here into the item hierarchy and just click on the horizontal container. So as you can see, it's really easy to go and select stuff inside the item hierarchy. And as well here we can go and have options. For example, let's go to the subcategories over here, right click on it, and with that we will get all the options of the worksheets, or if you go to the containers, you will get the containers option. So the item hierarchy are really important in order to structure our dashboards. Alright, moving on, we're gonna go and learn how to drop objects inside a container. And now, just to make things easier, I just went through all the worksheets, I removed all the filters, legends, and so on, just to keep things simple. So for example, let's go and start with the horizontal container, drag and drop it to the worksheet. So now let's take an object like the sheet and drag it to the view. Tableau gonna show you different visuals to indicate what's gonna happen if you drop it. So for now, everything is gray and we have a clear border of the container. That means now we are dropping the objects inside the container. So once I release it over here, what's gonna happen if we go to the layout, you can see the horizontal container contains the worksheets. So that means with this action, we placed the object inside the container. Let's check another options. Let's go to the dashboard over here and take another sheets. So now if you drag it and as you are moving your mouse, you will find different shapes and different stuff. So for example, if you move your mouse a little bit to the left, you can see that the gray line is on the left side and the container, the blue container, is marked. This is gonna mean if you drop it, Tableau gonna add it inside the container to the left side. If you move it to the right, gonna happen the same stuff but to the right side. So as long as Tableau is highlighting the dark blue color for the border, it means we are dropping the objects inside the container. But now check this, if you keep moving your mouse to the right side, you will see that Tableau can change the color from dark blue to light blue. That means now we are dropping the objects outside the container. So let's go and do that. I'm just gonna drop it to the right side. And now let's go to the layout in order to understand what happens. As you can see, the first sheet is inside the horizontal container, but the second sheet is completely outside of the container. So if you just minimize it over here, you can see that it's not inside the horizontal container. So that means you have to be really careful how you are dropping the objects inside dashboards. Tableau gonna react differently depend on the shapes. So now let's go and drag a third one. Let's take the customer distribution. So now as we are dragging, so here you can see that Tableau is highlighting the container because the mouse is inside the container. So here we can drop it either to left, right, bottom, on up. But if I move my mouse completely outside, Tableau can drop it outside of the container. So for example, I can put it to the left, to the right, to the bottom, but all of those stuffs are not inside the container. So now let's go back to our container. I will drop it to the bottom. So let's go and do that. And of course, to check what happened, we're going to go to the layout in order to check the item hierarchy. So now as you can see, Tableau changed it from horizontal to vertical container because we have dropped it below. And you can see that this object, this sheet, is inside the container. Alright, so that's it. Be careful how you are drag and dropping stuff inside Tableau dashboards. Okay, moving on to the next one. In Tableau, we have two different options on how to arrange our objects inside the dashboards, and we have the tiled and floating. As a default, Tableau gonna use tiled option for all our objects, but you can go and switch it to floating. So what those objects means? Let's start with the first one, the tiled option. If you use this option tiled, Tableau gonna go and automatically arrange your object as a grid layout. So that means, for example, if you go and resize the dashboard, Tableau gonna go and automatically change the size of all objects inside the containers and dashboards. So let's take an example. Now we are selecting the tilde, and if you take anything like the sheet over here and place it inside our dashboards, Tableau gonna go and automatically use the whole space. So that means the worksheet's gonna take the size of the dashboards, because Tableau gonna say, okay, we have a lot of spaces, let's go and use everything. But the other option, we have the floating in the other hand. Here, if you select it, here you have the freedom, the flexibility on how to customize the objects. And another advantage of the floating is that we can go and do overlapping between the different objects. But the disadvantage of the floating is that it's time consuming and you have to do everything manually. So now let's check how this works. Make sure to select the floating. Let's take another sheet and just drop it wherever you want. So as you can see, we have now gray box indicate the place where we are putting the charts. So let's drop it over here. And now we have the full control where to position this object. So for example, let's go to this icon over here and just drop it on top of the old one. So as you can see, we are now just overlapping, or we can change the size as we want. So I just can make it like this. So as you can see, we are having the full control of this chart, of this object, without any limitations. So now the question is, should I use floating or tilde? Well, in Tableau projects, you're gonna end up using both of them. And we normally use floating for the big containers inside the dashboard layout, and the tilde for all objects that we have inside those big containers. Alright, so those are the main options on how to work with the containers in Tableau. But of course, the best way to understand the containers in Tableau is that to have a real project. And that's why as a next, we're gonna have a mini project in order to understand how to design and build the layout of our dashboards using the containers. Alright, so now the task or the project is to create a dashboard for the sales. And one of the first steps that we usually do in order to plan our dashboard is to create first a sketch. So here we're going to go and draw a very simple sketch for the sales dashboards, where first, for example, we have the title of the dashboards, like the sales performance. And then beneath it, we're going to have three big numbers or three bands. So we have the total sales, the total profits, and the total quantity. And then beneath that, we're going to have three different charts. The first one on the left one, we're gonna have a bar chart in order to show ranking or the top sales by category. And then on the right side, we're gonna have two charts. The first one gonna be a line chart where we're gonna go and compare the sales with the performance. And below that, we're gonna show the sales by category using a pie chart. So with that, we have a sketch, we have a plan on how to visual our informations inside the dashboard. Now in the next step, we have to go and plan the structure of our dashboards in Tableau using containers. So if we're gonna go and translate this sketch to containers, we're gonna have one big vertical container that has three objects on top of each other. We have the title, then the bands, and then the charts. And since they are on top of each other, we're gonna use the vertical container. So now we're gonna go in more details in each information. So let's start with the first one. We have the text. In the text, we don't have any other informations like beneath it or side by side. That's why we will not use any container here. And then moving on to the next information, to the bands, as you can see, they are side by side. That means we can go here and use the horizontal container. So that means the horizontal container is inside the vertical container. Okay, moving on to the next one, we have the charts, and here it's going to be a little bit tricky. So first, if you check the sketch, we have like charts side by side, left and right. That means we're going to go and use the horizontal container. So again here, this horizontal container is going to be inside the big vertical container. And now if you check the right side, you can see that on the right side we have two charts on top of each others. So that means on the right sides we can go and use the vertical container in order to cover those two charts. So this vertical container gonna be inside the horizontal container, and both of them gonna be inside one big vertical container. So as you can see, everything makes sense if you are organized and you start sketching and planning your dashboards. So now we have a plan enough. Let's go to Tableau and start creating this structure. Alright, so now we're gonna start from the scratch. We have one empty dashboard. And now let's go and follow our plan, where first we're gonna have the main container, the vertical container. So let's take it from objects, the vertical container, drag and drop it to the dashboard. And now as you can see, if you don't select anything, it's going to be still a white page. In order to have an identifier for this container and make it easier to see during the design, what I'm going to do, we're going to go to the layout over here. So select the container, and then we're going to have a border for it. So let's go to the border over here, make it a line, and then let's make it a little bit heavy and give it the color of orange. So now if I deselect, you will see that we have one big container, the orange one. And this can indicate for me, this is a vertical container. And as well, what we can do, we can go to the item hierarchy hierarchy over here and give it a name. So let's go and give it a name. So now let's call it the main vertical container. All right, so what do we have inside this container? Three informations. The first one going to be a text, so the title of the dashboard. So let's go to the dashboard over here and grab our text object and drop it inside this container. Let's call it sales performance and big, get a little bit big. So let's make it 2022 bold. Okay, so that is the first information. The second information that we're gonna go and add a horizontal container for the different pans. So let's go to the object over here and grab the horizontal container and just put it beneath the text. So now with that we got a horizontal container, and let's go and make an identifier for that. So let's go to the layout, make a border, and now we're gonna give it the color of blue. So now we can see that we have a blue container inside the orange container, and we can go and give it a name. So let's go to the hierarchy and let's give it the name of pans. And now what we're going to do, we're going to go and add blanks inside this container in order to have a placeholder for the actual pans. So in our plan, we're going to have 3 pans. What we're going to do, we're going to go to the dashboard. Let's go and add 3 blanks. And as you can see now, we have it very small since it's blank. Let's make it a little bit bigger. And let's go and add the second one to the right side and another one to the right side. So now what we're going to do, we're going to go to the layout and go and check the structure over here. So as you can see, everything is fine. Those blanks are inside the horizontal container. All right, so that's all for the container for the pans. Now next information, we're going to have the charts. So again, here we're going to go and add as our plan a horizontal container beneath this one over here. And as usual, we're going to go to the layout and give it a color and as well a border. So now as you can see, we have one container beneath another container, and both of them are horizontal containers. So let's go and give it a name. We're going to call it charts. And now we're going to go and add the blanks, the placeholders for the charts. So what we're going to do, we're going to grab a blank over here. It goes again small. Let's make it bigger. The second one to the right side. And with that, we got the left and right. So now as usual, we go back to the layout and check whether everything is fine. So you can see those 2 blanks are beneath the horizontal container. And now as you can see, I'm always going back to the hierarchy in order to check whether everything is fine. And here is exactly my tip for you, is always to check. And don't leave it until the end. So don't check the item hierarchy at the end after you drop everything in the charts. I promise you will see stuff here that you didn't plan. So always as you are dropping new stuff to the dashboard, go and check the item hierarchy whether everything is fine. Alright, so now only on the right side over here, we're gonna have 2 charts on top of each other's. So that means we can have a vertical container only on the right side. So let's go to the dashboard over here. And now I'm going to go and remove the right blank, because instead of that, we're going to have the vertical container. So let's click on this blank over here and drop it. And then let's go and get our vertical container and just put it to the right side. So make sure it's placed on the right side and we're still inside the container of the horizontal container. So let's drop it. And now you can see we have something on the right and something on the left. So let's make it a little bit bigger to the middle over here. Let's go back to the layout and check everything is fine. So as you can see, we have the horizontal container, this main one, and then inside it on the left, it's blank, and on the right, we have the vertical container. So let's go to the right side and give it a color. So it's going to be a border, and this time gonna be orange. And inside this container, we're gonna have 2 charts. So I'm gonna go with the blanks again and put it here inside underneath each other's. And now let's go back to the layout, and as you can see, we have those 2 blanks for the charts on the right side and 1 big blank for the left one. So now the next step, what we're gonna do, we're gonna go and make sure that everything is distributed evenly. So let's start with the container on the right side over here, right click on it, and let's click on distribute contents evenly. And then let's go to the next one, to the horizontal container for the charts, right click on it and distribute the content evenly. And then we're gonna go to the next one, right click on it and distribute things as well evenly. And now for the last one, for the main container, I will not do that because things here has different sizing. So the text gonna be smaller than the pans and the charts gonna take the most of the space. Alright, so with that, as you can see, we have built the basics for our dashboards and we have implemented our plan. So now the last step, we're gonna go and bring the content inside our containers. So let's go to the dashboards over here. So let's start with the pans. So let's take the pan sales, then the profits, and the quantity. And what we're gonna do, we're gonna go and remove those blanks since we don't need them anymore. And now things here don't look really nice because here we have titles. So let's go and remove the titles from each one of them. and as well we would like to have everything in the center. In order to do that, click on the objects and go instead of standards to entire view, or for example if you go over here to those more options, fit and then entire view, and for the quantity we're gonna go and switch it to entire view. So with that we have our 3 pans as planned. The next thing we're gonna have the bar chart on the left side in order to show some ranking. So let's go and grab our bar charts, and what we're gonna do, we're gonna go and remove the placeholder, the blank, and then the next step we're gonna go and add the last 2 charts. So first we have the line chart, it's gonna be sales versus profits over here, and as well I'm gonna go and remove the blank, and the last one is gonna be the pie chart, so sales by category. So let's drop it over here and remove its blank. So now the next step we're gonna go and make sure that everything has entire view, same for the pie. Alright, so as you can see, as we have a solid structure, everything else is gonna be easy. We are just drag and drop stuff and removing the blanks. So now with that we have everything. Let's go and remove those borders. So let's go to the layout and go to the first one. Let's remove the border to the horizontal as well, remove this, and all our containers removed. Alright, so with that we have our dashboards, and of course we can go and add a lot of designs and a lot of customizations. For example, we can add a border for all those pans. So let's go and do it just quickly. So we can add a gray border for each of one of them in order to separate them. And with that we have built a very organized and simple dashboards in Tableau using the power of containers. So as you can see, it's very easy once you organize your stuff and do it step by step. Instead of rushing things and dropping your charts immediately to the dashboard without any plan, it's gonna be really hard to control, and as well the look and feeling of your dashboards gonna be really bad. Especially if you want to add more elements with the time, it's gonna be really hard to extend your dashboard. Slow down, make a plan, and then implement it using the containers in Tableau, and at the end bring your content. Alright, so that's all about dashboards in Tableau. Alright, so with that we have a solid foundations about the Tableau dashboards. In the next section we're gonna do a real Tableau project where you're gonna learn how to execute Tableau project step by step. Tableau projects. Now we're gonna work together in order to implement Tableau project. But what's special about this project is that you will not only learn how to work with Tableau, but also you will learn how I usually implement projects in big companies. I'm currently leading big data and business intelligence projects in Mercedes-Benz. So that means I'm sharing with you now a knowledge, a real life skills on how we implement stuff in real projects. It's not just another online course. So I'm gonna take you in the project from the starting point, the user requirements, and we're gonna end up by having a wonderful Tableau dashboard. So the first step, we're gonna go and analyze the user requirements. We're gonna design and draw a dashboard mockups, and then the first step in the implementations, we're gonna prepare our data source, and after that we're gonna start building the different charts. And once we have all the charts, we're gonna start planning our dashboard containers, and we're gonna start building and designing the dashboard. So let's start first by understanding the phases, the steps of any Tableau project. So now let's go. Tableau projects are like any other projects. For example, building a house. The first thing is that we have to sit with the users and understand their requirements and their wishes. So that means we have to analyze the user requirements, and then before starting constructing the house, the architect gonna go and create a blueprint and the layout by defining the structure of the house and the rooms. And then after everything is planned, the foundations of the house gonna be created, and this is very crucial step in the construction. And now once the foundation is finally stable, the construction gonna be starting by building the floors, walls, roofs, and so on. And the last phase, it is the finishing touches by adding doors, adding electricity, choosing the paint colors and the decorations. So the project phases of building a house is very similar to a Tableau project. And here I'm gonna show you now the different phases that I have usually in each Tableau project. So the first phase of each Tableau project, we're gonna start with collecting and analyzing the requirements. So here first we have to understand the user requirements. Then we have to go and decide on which chart types we're gonna use for each requirement. And then together with the users, we're gonna go and draw the first mockup of our dashboard and as well decide on the colors. Then after we have understood the requirements, we can go and start building stuff in Tableau, and we start with the first step by preparing the data source. And here we have the following steps. First, we have to connect our data. Then we have to build a data model. And then the last step is that we're gonna go and understand the data model and the data inside our data source. Then once we have have a solid data source, we can start building our charts. And here we have different steps. First, we have to check whether we have all the data inside the data source, or we have to create a new calculated fields. And then once we create those calculated fields, we have to go and test them first before we start building any charts. And then after that, once we have all the data that we need, we can start building the charts. And then once we have the basic charts, we're gonna go and start formatting it by adding colors, removing grids, editing the axes and the headers. And now once we are building all our charts using the worksheets, we're gonna go to the last phase where we're gonna start building our dashboards. And now for this phase, you have to slow down and start planning everything step by step, and rushing in this phase will not help you at all. So first we start planning the whole structure of the dashboard by planning the containers. And once we have a plan, then we go to the next step where we start building the foundations. We start building the containers of the dashboard. And once we have a solid structure, we're gonna go and start adding the content to the dashboard. And after that, we're gonna have the step where we're gonna take care of the filters and the interactivity inside our dashboard. And then the last step of building a dashboard, we're gonna have the final touch by adding icons, like icons for the logo, icons for the filters, or for navigating between dashboards. Alright, so those are the main phases of building a dashboard in Tableau. And here, of course, my recommendations to take it step by step and don't rush things, otherwise you're gonna end up by chaos. And it's gonna be as well really hard to maintain the dashboard later. So don't rush building the dashboards, always take time in analyzing the requirements, understanding the data, planning the structure, planning the mockups, and by that I promise you're gonna deliver a professional work. Alright, so now I'm gonna start with the Tableau project from the scratch, where I'm gonna show you step by step how I usually implement projects using Tableau. And we start right now. Alright, so the first step in each project that we do is that we're gonna go and sit with the users in order to understand their requirements, their wishes. And we usually document the requirement in something called user story. So now we're gonna go through these requirements. I'm gonna leave the link in the description, and then we're gonna go and start choosing the right charts for each requirement. So the user story or the project is about sales performance. And here in the introduction, it says we have to go and build 2 different dashboards using Tableau to help the managers, the stakeholders, in order to analyze the sales performance and as well the customers. So that means we're gonna go and build 2 dashboards inside Tableau. So let's start with the first one, the sales dashboard. The main purpose of this dashboard is to provide an overview of the sales metrics and trends. And here it says in order to analyze year-over-year sales performance. So that means here we are comparing 2 years together. Let's check the key requirements in these dashboards. So the first one is that to provide an overview for the KPI, where we have to display a summary of total sales, profit, and quantity for the current year and compare it to the previous year. So that means in the dashboard, we don't have to present all the sales, we have to present only the sales of the current year and as well the previous years. And now let's go and decide which type of charts that we have to present for these requirements. We can go with the bands. Bands are very useful in order to show the main metrics like the total sale, profit, quantity in big numbers. So for this requirement, we're gonna go and create bands for it. Let's go to the next one. We have the sales trends. Here we have to present the data of each KPI. That means the total sales, profit, quantity on a monthly basis. So here we are talking about change over time, right? For both the current year and compared to the previous year. And as well here they want us to identify the months with the highest and the lowest sales. So that means we have now to choose a chart that presents change over time. And for this, you can of course discuss it with the users and show them different types of charts as we learned before. So for now, I'm gonna go with the line charts. And precisely, we're gonna go and use the spark line charts in order to highlight the max and min values. Alright, moving on to the third requirement, we have the product subcategory comparison. So here we have to compare the sales of different subcategories for the current year and as well the previous year. And it says as well, we have to include in the comparison as well the profits. So here we are comparing multiple stuff. First, the subcategories with each others. We have 2 measures, the sales of the current year, the previous year, and as well the profits. So here we can understand that we are comparing the members of the subcategories, and for that we can use the bar charts. And since we have 2 values, the current year and the previous year, we can use, for example, bar in bar charts. And then for the second point, in order to compare the sales with the profit, we can present as well another bar chart side by side to the sales in order to show the profit informations. Alright, so moving on to the last one, we have the weekly trends for sales and profits. So here the requirement says we have to present the weekly sales and profit data for the current year. So here we are talking about change over time because we have the time aspects, and we have to display as well the average weekly values. We have to highlight the weeks that are above and below the average in order to understand the trends in our charts. So here again we are talking about change over time, but on the weekly basis. We have it before as a monthly, so here we can go as well with the line chart in order to compare the sales and profits. Alright, so with that we have covered the main requirements of the sales dashboards, and as well we have a plan on which charts to be used for which requirements. Alright, so now we're gonna move to another type of requirements. We have the interactivity requirements. So here it says that the dashboard should allow the users to check the historical data by allowing them to select any desired year and not limited to just the current year or to the last year. So that means the dashboard should be dynamic, where the users select the year that they want to compare it with the previous year. So it should not be always the last current year. And for that we can use parameters in order to solve this task. Then we have the second requirement. It says that we have to provide the users the ability to navigate through the dashboard very easily. And for that we usually buttons inside our dashboards in order to switch back and forth between the dashboards. And the next requirement about interactivity is that the user should be able to filter the data using the charts. And for that we can use dashboard filters. And now moving on to the last one, it's about data filters. So we should allow the users to filter the data by product informations like category and subcategory, and as well by the location like region, states and city. So that means we have to provide all those filters inside our dashboard as well. Alright guys, so with that we have covered the first two steps inside our project, where we understood the user requirements, and as well we have decided and choose the right charts for each requirement. Let's move to the third step, where we're gonna build a mockup for our dashboard. Alright, so this is how I usually draw a mockup for a dashboard in Tableau. So as usual, it starts with the title. So it's gonna be sales dashboard, and we can put as well in the title which year is currently selected. So it's gonna be, for example, the current year 2023. And now below that we can have our pans, right? So we're gonna have three sections or three pans for the total sales, total profit and total quantity. And now in each of those blocks we're gonna show the following informations. First we have to show, of course, the total. So we're gonna show the total sales as a big number, and then below it we're going to show the difference in percentage to the previous year. And since we are talking about KPIs, we have always to show a symbol in order to show the performance of the current year. So it's going to be either up or down. So with that we have covered the first requirement. The second requirement is to present the data on monthly basis and compare the current year with the previous year. And for that we're going to use the spark line in order to show the curves and as well the progress of each line. So we're going to have two lines, one for the previous year and one for the current year, and we're going to show the max and the min values using like a circle that we can position it on the lines. So with that we have covered as well the second requirements, and we're going to do the same stuff for each KPI. So we're going to do the same stuff for the profit and as well for the quantity. Alright, moving on to the third requirements, we have to present the subcategories comparison. So we're gonna go and use the bar in bar chart in order to compare the current with the previous year. So for that we're gonna have the background bar in order to present the previous year, and the current year gonna be the one in the front. And what is missing here is the profit, so we're gonna present the profit side by side to the sales to the right side, and as well using the bar charts, and the profit could be plus or minus. And the next info that we're gonna present in this chart is the profit side by side by the sales, and as well it's gonna be a bar charts where it's gonna have plus and minus values. Alright, moving on to the last requirement, we're gonna have the weekly trends for sales and profits, and here as well we can use the line chart since it's change over time, and we're gonna have two sections, one for the sales and one for the profits. We will not bring them together in one because we want to show the average line for each metric. So that means we're gonna have a reference line in order to show the average for the sales and as well another one for the profits. And then we have to go and highlight using the colors the data that is above the line and below the average line. Alright, so with that we have covered all the charts inside our mockup. Of course we have to add different stuff like a filter. So since we have a lot of filters and there will be no space inside our dashboard, I'm sure about that, we're gonna go and have an icon in order to show and hide the filters. So that means we're gonna have a dedicated section where we can put all our parameters and filters like the product filters and the location filters, and the users can go and hit the button in order to show or hide this section. And now we come to a very interesting part of the design of our our dashboard is that we have to decide on the coloring. And it's very important to decide on the coloring at the start of the project so that you don't have to adjust a lot of stuff later. So you have to decide on the coloring as you are creating the mockups together with the users. So what I usually do, I use maximum of 4 colors inside the dashboards. So the first 2 colors are the basic colors, and they really depend on the background color of Tableau. If you are using the white color as a background inside the dashboard, then I usually go with a very dark gray and a light gray. So those 2 colors are the basics that I usually use in each dashboard that I create, and the other 2 colors really depends on the user's preferences. You can let the users to decide on those 2 colors, or you can take it as well from the icon of their logo. So as you can see in the mockup, we are not designing only the chart types and the position of the charts inside the dashboard, but also the coloring of the dashboard. So now here the final touch that we can add to our mockup is that we can add a logo for the dashboard, and as well we can add that dynamic where we can switch to another dashboard by using buttons. So here, as the requirement says, we have 2 dashboards. We have the sales dashboard and the customer dashboards, and we can introduce on the header of the dashboard 2 buttons in order to switch between those 2 dashboards. So if the users clicks on the customers, it's gonna switch to the customer dashboards, but if the users clicks again on the sales, it's gonna switch back to the sales dashboards. Alright, we will not design now the customer dashboard. I'm gonna leave it for you in order to practice. We are focusing only on the first part of the requirements of the sales dashboards. Alright guys, so now we have a mockup, we have a blueprint, and if the users agrees on this blueprint, we can go and execute our plan, and we can start building that in Tableau. And we will start by preparing the Tableau data source. Alright, so far we have understood the requirements, and as well we have a mockup for our dashboard. The next step is that we're gonna go to Tableau and start building stuff. Alright guys, so the first step is to prepare our data source, and I promised you to start from the scratch. That's why we're gonna start our Tableau public as an empty where we don't have anything inside it. So now the first thing is, of course, we need our data. Go to the link in the description and download the data that I left there for the project. Then we're gonna go and connect it. So in order to do that, we're gonna go to the left side over here. So make sure you are at the home page or the starting page of Tableau. So let's go to the text file. And then here previously we worked with the big and small data source. Now we're gonna work with the Tableau project's sales dashboard. So let's go inside it. And here we get files which has similar informations as the old data sources. So let's go and select something over here and click open. So now we are at the data source page, and as you can see, we have connected now our data to Tableau. Alright, so the next step is that we're gonna go and create our data model inside the data source. So here we have to go and understand our data. I'm just gonna go and remove this from here in order to have everything from scratch. So we have to understand our data inside those files in order to know what is dimension and what is fact. So let's go for the customers over here and click view data. And as you can see here, we have only 2 columns, customer ID, customer name. This is the dimension. It doesn't have any facts. So that means the customers table is a dimension. Let's go and close it and go to the next one. We have the locations. Let's go inside and check the data. As you can see, we have city, country, region, states, and so on. Those informations are dimension informations as well because we don't have any events inside it. So it's not really a fact. Let's go and close it. Let's check the third one, the orders. So now we can see over here we have some IDs like the customer ID, order ID, product ID. Then we have some dates, like for example here the order date. We have the ship dates, and as well some numbers like the sales, quantity, profit, and so on. So this is an indicator that this table is a fact because we have a lot of measures, and as well we have dates, which can indicate that this table contains events. So once you see such a setup where you have IDs, dates, and measures, this is a big indicator that this table is a fact. So the orders are facts. Let's go to the last one, to the products. So here we can see that we have the product ID, category, product name, and so on. Those informations are a dimension. So that means this table, the products, is a dimension table. Alright, so with that we have now an overview of our data, and we can start moduling. In Tableau data source, the first thing that we can start is by drag and dropping the facts. So that means we're gonna go and get the orders and put it in the data model over here. And then after that, we start bringing all other dimensions to the data model. So let's take the customers, for example, just drag drop it over here as a relation. And now as you can see, Tableau is gonna create a relation. It's very important to check the relationship. So as you can see, we have the customer ID equals to the customer ID, which is correct. We will leave all other options over here in the performance as a default. Since we don't deal now with the performance, first we have to build stuff and then check whether the performance is bad or good. So at the start, leave everything as a default. Let's go to the next one, get the location, drag and drop it as well over here. And we're going to check as well the relationship. It's going to be the postal code equal to the postal code as a key. And the last one, we're going to get the last dimension, the product, and drop it to the data model. And as well, we're going to check the relationship. So as you can see, we have the product ID equal to the product ID. All right, so with us, we have our data model where we have one fact and all the dimensions are connected to this fact. And now the next step is that I'm going to go and start changing the names around. So for example, let's go and rename our data source to sales data source, and then we're going to go to the table names and remove the CSV. So right click on it and let's rename. So let's remove the extensions and as well for everything, just to have it nice in the data model. So with that, we have very nice naming in the tables. All right, so this is about the renaming. The next step is that we're going to go and check the data types for the fields, whether they are correct or not. Sometimes if you have bad data quality from the sources, you will get strange data types, which can make later a lot of issues if you don't check the data quality at the start. So let's do it quickly. We're going to go to the products, and as you can see, everything here, we have like characters and the data type is a string. So everything is fine to the products. Let's go to the locations. And now we can see that all those informations are geographical informations. And as you can see, all the data types are correct beside the region over here, so we can go and switch it to a region. So let's click on that and go to geographical role, and here we have the type of country region. Let's go and select that, and we can see that all of them contain characters and they are the data type of string, so everything is fine as well in the customers. Let's go to the orders, and here we have a lot of fields. What is very important to focus here on the date field. So as you can see, the order date and the shipping date, both of them has the data type date, which is really perfect. And in many situations I see a lot of informations as a date, but the data type is string, and that's because we have corrupt data inside those fields. And now the next important thing to check inside our data, we have to go and check our numbers. So let's make sure that all our numbers has the data type number. So as you can see, all our fields has the data type number, and this is really important because we want those numbers to be continuous measures in order to build the charts. So that means if you have any of those informations as a string, what can happen? Tableau gonna think this is a dimension, and then you cannot use it in your visuals to do aggregations like sum and average because it's a dimension. So that's why it's really important to check that all your numbers has the data type number in order to have it as continuous measure. Alright, so with that we have very good and solid data source. The next step is that I go and try to understand the data before I start building visualizations. So let me show you what I mean. Let's go to the worksheet page and let's start just randomly check the data inside the data source. So all what I want now is to get closer to the data, to the content of those tables, because normally in projects we have a lot of tables, and if you don't understand the content of the tables, it can be really hard to find your informations and build the correct charts. I know that we have practiced with most of those informations before, but I wanted to show you what are the steps that I usually do inside the projects in order to build really nice visualizations. So now I go, for example, and check, okay, what is category, which values are inside it, and with that I can see that we have 3 values. That means we have low cardinality inside the category. And then I go, I check another example, let's say the subcategory, drag and drop it over here, and I can see that, okay, there is like hierarchy between those 2 dimensions. And then I go and take something else like the segments over here, and now we can see that we have a lot of duplicates inside the data, which means maybe there is no relationship between those 2 dimensions and the segments. So if I drag it to the start, still there is like duplicates, so there's no relationship between those informations. So I go and drop those information, I can see, okay, we have 3 segments. So those are actually segments of the users and not for the product. So as you can see, step by step we are learning the data inside our data source. But then the next step, which is interesting, do we have a lot of countries inside our data source? So let's drag and drop the country. As you can see, we have only 1 country, so this data is about the USA data. Then interesting, which regions do we have inside the data? So we have all 4 regions and states and so on. So as you can see, I'm just browsing the data. So this is really important step in order to understand the business and start discussions with the users of those dashboards that you are creating. Reading your data, understanding your data before creating any charts or any visualizations. Alright, so now once you are done browsing and understanding the content of our data, we can go to the next step where we're gonna go and start building our charts. Alright, so now we're gonna start implementing the requirement by creating the charts, and we're gonna start with the first charts where we're gonna go and build bands. So the requirement says display a summary of total sales, profits, and quantity for the current year and the previous year. And let's not forget the requirement that it says the dashboard should allow users to check historical data by offering them the option to select the desired year to be the current year. So now let's start with the first band where we're gonna focus on the total sales. So now let's go to our data, let's go to the orders, sales and check the informations that we have inside the sales. Let's grab it to the text over here. And now with us, we have the total sales inside our data for all years. But the requirement says we have to show the total sales for the current year. So let's take, for example, the order date and put it to the rows over here. So as you can see now, we have the sales for all years and not only for the current year. So that means I need field that shows only the sales for the last year, for 2023. In order to do that, we have to go and create a new calculated field. So let's go and do that. And we're going to call it current year sales. And then the function is going to be really easy. We're going to check whether the current year is 2023. If it's true, then we're going to show the sales. Otherwise, we will show nothing. And for that, we're going to use the if condition. So let's go and use that. And then what do we need is the year of the order date, because the condition is based on the year. So if the year equals to 2023, then what can happen? We will get the sales, right? Otherwise, if it is not 2023, I don't want anything. So it's going to be null. So that's it. Let's end it. So again, the logic is very easy. We are checking the year of the order date. If it is 2023, then show the sales. If it's false, then don't show anything. It's going to be null. So let's go and hit OK. And with that, we got a new calculated field, the current year sales. Let's go and grab it to the view over here to check the data. So now, as you can see, this field now is showing us only the sales for the current year 2023. So this is for the first fields, but in the requirements it says we need as well to show the sales of the previous year. That means we have to show the sales of the 2022. So in order to do that, we have to create as well again a new calculated field to fulfill this requirement. So let's go to the current year sales and go duplicate it in order to create the new calculated field. So let's go and edit it. So now what we're going to do, it's really simple. Instead of having 2023, we're going to go and make it 1 year less. It can be 2022. All right, so let's go and hit OK. With that, we have the previous year of the sales. So now let's go and check the values. I'm just going to take it and put it here in between those two values. And with that, as you can see, we have the previous year of sales. So with that, we have the sales of 2022. So now we have the two main calculations for this project. We have the current year and the previous year for the sales. So how to make those two fields dynamic? We can go and use the parameters in Tableau. And now before we create the parameter, we have to create one more calculated field in order to have the years of order dates, so that later we can use it inside the parameter. So let me show you what I mean. Let's go and create a new calculated field. Let's call it order date. And it's going to be the years. And then what we're going to say, we can use the function year, and inside it, we're going to have the order dates. So this field going to return always the years of the order date. So that's it. Let's go and hit OK. And now we're going to go and create our parameter. So right click over here and create parameter. Now we have to go and give it a name. It's going to be select year. And the data type going to be integer, since it's going to be years, so there is no float. And now we have to define what is allowed to be used as a value inside this parameter. If you leave it all, then the users can go and insert anything, which is not really good, because then the users have to go and guess how many years do we have inside our data. But instead of that, we have to give them a predefined list of all years that we have inside our data. And for that, we're going to go and check a list over here. And then the values inside this parameter are going to come from the new calculated field that we called it years for the order date. So let's go over here, add value from, and then we're going to go and pick our new calculated field. This is really good, first, because it is automatic. You don't have to go and manually add all those years. And second, later maybe you get a new year inside your data and you don't have to go manually and adding those informations. It's going to be automatically added to the list. So we are almost fine, but I'm not really happy with the format. As you can see, we have here the thousands point. So let's go to the display format. And what we're going to do, we're going to go to the number custom. Let's remove all those decimal places. And as well, the display unit is going to be none. So that's it. So what we're going to do, we're going to go to the number custom over here. Let's remove all those decimal places and as well remove the thousand separator. All right, so that's all. Let's click over here. Then as you can see, we have now the years without any separator. That thing that we have to go and make the current value as the last year. So let's go to the current value over here and select 2023. So that's all for this parameter. Let's go and hit OK. And as you can see, we have it on the left side now, the parameters. Let's go and show it for the users. So show parameter to the view. And now the users can go over here and start selecting what is the current year. So as you can see, if I'm selecting the years, nothing is changing inside our view. And that's because we haven't now linked this parameter inside the calculation. And this is exactly our second step. So let's go and do that. Let's go to the current year sales over here and let's go and edit it. And now instead of this static value, the 2023, we're going to go and add our parameter. So let's write the name of the parameter. It is select year. And that's it. So what you are saying now, if the year of order date equals to the the selection from the user, then show the sales, otherwise show nothing. So let's go and hit OK. And let's go and try that. So let's focus on the current year sales and let's go and change the value to 2022. And as you can see now, the current year for the sales, it is the 2022. And the same if you go over here and make it 2021. So as you can see, everything is dynamic and the users now can go and select what is the current year. So now the next step with that, we're going to go and integrate it inside the previous year. So let's go to the previous year, edit it. And the same thing, instead of 2022, we're going to say select year. But now since we are talking about the previous year, what we're going to do, we're going to go and subtract 1 year. So that's it. Let's go and hit OK. And now let's go and test again. So 2023, everything is fine. Let's go and switch the current year to 2022. So let's do that. And now we can see that both of those two values did react to our selection. So now the previous year is 2021 and the current year is 2022. So with that, we have completed the first requirement inside our user story where the users can go and decide which year gonna be the current year. And we made it completely dynamic using the parameters. All right, so with that, we have our main calculations for this project where we have the current year and the previous year of the sales. So now the next step, as we decided in the mockup, we want to show the differences between the current and the previous year. And we're gonna have it as percentage in order to show the KPI. So let's go and create a new calculated field and we're gonna call it percent difference sales. So the calculation can be really easy. So we're gonna go and subtract the current year of sales from the previous year of sales. But now since we want to present it as a percentage, we have to go and divide it by the previous year. So let's add starting and ending brackets and divide it by sum of previous year. With that, we will get the percentage of the differences between the current year and the previous year for the sales. So let's go and hit OK. And with that, we got our new calculated field. And now what we're going to do, we're going to go and change the format to percentage. So right click on that. And then let's go to default properties, number format. And now let's go to the percentage and let's have only one decimal. Let's hit OK. Now in order to show those values here, let's go and remove the year. And now let's go and check the value of the differences between the current and the previous year. And with that, as you can see, the differences between the current year and the previous year is around 29%. So again, we can go and check our parameter to see whether everything is working fine. So let's go to 2023. As you can see, the difference now is only 20%. All right, so with us, we have almost everything that we need in order to build our first pane. So I'm going to call this first sheet as a test in order just to test the data. So let's go and create a new worksheet, KPI sales, and we can start building our first charts. So now if you check our mockup, our KPI has two parts. The first part going to be the bands where we have the big numbers, and the second part going to be the spark line. So here we have two options. Either we're going to go and make a dedicated sheet for each section, or we make everything in one sheet, like the whole KPI in one sheet, and we're going to do that. So what we're going to do, in the title, it's going to be the band. So we're going to put all the informations of the band inside the title, and then inside the view, we're going to go and build our spark line. So let's start with the bands first. What do we need for informations is the current year of sales. Let's go and grab it on the details. And then the second information that we need is the difference of sales. So let's grab it as well to the details over here. And that's it for now. Let's go now to the title and start building the band. So double click on the title. And now in the first line, we're going to give the name of the measure. So it's going to be the total sales. And then the second information, it's going to be the current years of sales. So let's go to insert over here and add the sum of the current year sales. And the third information is going to be the differences. So a new line, and let's go and add our calculation, the difference of sales. So now let's go and hit apply in order to see the information. So as you can see now, we have total sales, we have the total number of sales for this year, and as well at the end we have the differences. So now we're going to go and start formatting this band. So what we're going to do, we're going to go over here to the total of sales. Let's make it the font Tableau book, and then let's go and reduce it a little bit more to 14. And now the next thing, we're going to go to the total sales and we're going to make it really big. So let's select that. Let's take the font to bold, so Tableau bold, and then let's go and increase the font to, for example, 2022 and make it bold as well. So here we have really to make it really big. So let's go and hit apply just to check the numbers. So as you can see, we have total sales small, then a big number, which is really great. So now for the next one, we're going to go and select it. Let's choose, for example, the Tableau semi-bold, and then make the size to 20. Then we're going to go and add the text of versus previous year. All right, so let's go and hit apply. So now everything looks fine. This information is not really relevant to show it very bold inside our data. So let's go over here and change the font back to Tableau book. And as well, let's go and change the coloring as well, something like here, really light gray. So as you can see, everything looks fine. Now let's go and change the coloring and the format of the text, because this is not really irrelevant information. So we're gonna go over here and change it again to Tableau book, and then let's go to the coloring and make it like light gray little bit. So let's go and hit OK. Now you can see that our band look really nice. So let's go and hit OK. What I'm gonna do, I'm just gonna go and change the format of the total sales. So right click on the current year of sales, and then let's go to format. Then instead of having the axis, let's go to the pan over here and go to the format of numbers. Let's go to the number custom. Remove the decimal numbers. Let's have the unit as thousands in order to make it more easier to read, and let's add the $sign in the prefix. So now things looks more professional. So we have the $sign, and as well the number is rounded to 1000. Alright, so now the next what is missing inside our KPI, if you look to the mockup, we have decided to add the KPI symbol. So we need an icon to indicate whether the sales is going up or going down. In order to do that, we're gonna go to the differences and change the format. So let's go to the differences, to the formats, and then let's go to the format of number over here, and let's go to custom, and then we're gonna go and add the following format in order to indicate the KPI. I will leave this format in the description as well in order for you to copy and paste it. So here what we are saying, if the percentage is a positive number, it's gonna be up. If it is a negative number, it's gonna be down. And of course, if you want to add more decimals to the percentage, you can go over here and add a 0. So as you can see, once I add 0, the format gonna change. But now for that, I would like to have only 1 decimal. Alright, so that's all. So as you can see, now we have a really professional band where we have the total sales of the current year, and as well we have the differences between the current year and the previous year using a really nice KPI. So now of course we can go and test it. Let's go and show the parameter to the right side. And let's go, for example, to 2022. And as you can see, everything is changing perfectly. 2021. And now you can see the arrow is down because the previous year was higher than the current year perfectly. So with that, as you can see, inside the title, we have created the band. Now the next step is that we're going to go and create the spark line. All right, so now let's go and build our spark line. It's going to be based on the months. Don't forget the requirements. It's to show the current sales based on the month and then compared to the sales of the previous year. So first, let's go and switch the parameter to 2023, and let's go and get our order date to the columns. And now what we're going to do, instead of having years, let's go and switch it to months, and then we're going to go and grab the first measure. It's going to be the current years for the sales. Let's put it to the rows. And now instead of having discrete line, I would like to have it as continuous line. So let's go to the months over here, right click on it and switch it to continuous. So now what we're going to do, we want to compare it to the previous year. In order to do that, so let's go and get the previous years of sales. And now since both of the charts going to be line charts and going to be on top of each other's, we're going to use the measure names and values. So let's drop it on the axis over here. Now you might notice that we have broken our pan. So we have here like a range between the lowest value and the highest value. We don't want that, but we will fix it later. Don't worry about it. So now let's keep focusing on the spark line. So with that, we have our two lines. Now what is missing is to highlight the highest value and the lowest value of the current year. So now in order to get those two circles on top of our view, we have to go and add another measure. But first we have to go and calculate it using calculated fields. So let's go and create a new calculated field, and we're gonna call it min max of the sales. So now we're gonna go and search for the highest and the lowest values of the sales. So in order to do that, we're gonna go and check a condition using the if else statements. So let's start with the first one. We're gonna say if the sum of the current year, and now we're gonna go and check whether this value is the highest between all other current sales. So what we're gonna do, we can use the function of window and max, since we are searching for the highest value, and then inside it we are comparing all those current years. So current year of sales. So now we are just checking whether you are the highest value. If it's true, then what can happen? Then show the value. So sum of current year of sales. So that means if you are the highest value, then show yourself, show the value. Otherwise, we're gonna go and search for the lowest value. So else if, we're gonna take the same stuff, sum of the current year equal, but now instead of window max, we're gonna use window min. So I'm just gonna go and copy everything from here and replace the max with min. So now what can happen if you are the lowest value? We're gonna do the same, show yourself. So we're gonna show as well the value of the current year for the sales. Otherwise, we don't want to see any value. So what we're gonna do, we're gonna go and say ends. So that's it, the calculation is valid. Let's go and hit OK. So now we have it as a new field, but I would like to test the value, whether it's working. So instead of throwing it now to the visual, let's go into another sheet. Let's grab the order date to the rows, switch it to month. I just want to check whether everything is fine. Let's grab the current year of sales to the view. So now with that, we have the sales of each month. And now let's go and grab the new calculated field, the min max, and drop it over here. So now let's check the table. What is the lowest value? It's going to be the February. So as you can see, we have the min, and what is the highest value? It is November. So now as you can see, this calculation is working. So here my recommendation for you, if you are creating something complicated, always go and test on the table in order to see the numbers before you switch it to like circles or lines, because with those tables we can go and validate better. So let's go back to our KPI sales and let's grab our new value min max sales and drop it to the rows. So with that, we got our new charts because we have a new measure over here, and we have as well in the marks a new tab for the min max. So now let's go to this tab. In order to configure the min max, instead of automatic, we want to have circles, and as well we're gonna go and make it a little bit bigger in order to see those circles. So we have here the min and the max. And now let's go to the first chart. So we're gonna go and switch it over here and make sure instead of automatic it's a line, because we're gonna go as a next and merge those two charts in one. So in order to do that, we're gonna go and use the dual axis. So right click on the min max over here, use the dual axis, the axis on the right side, and maybe just hide it from the right side over here. So as you can see, we have now those circles on top of our line charts. And with that, we are highlighting the highest and the lowest value inside our spark line. So now we have our spark line, but now let's go back to our pan and fix it. So as you can see, we have a range, and that's because inside the view, we are using the month as continuous fields, and Tableau gonna go and make it as a range. And this is the disadvantage of having everything in one chart. They are like related to each others. So what we're gonna do, we're gonna go and fix it by doing the following. So now in order to fix this, we're gonna use a trick in order to make it fix and does not like react to the things that we have inside our view. So let's go and double click on the first one, and we're gonna add at the end open brackets. So let's add it at the end and as well to the starts, and let's go and hit OK. And as you can see, nothing is changed because we have to go inside the title and change stuff, but let's keep changing those stuff. Let's go to the second one, double click on it, open brackets at the end, and let's add it to the starts. So let's go and hit OK. So now the next step is that we're going to go inside the title and start fixing it. So double click on it. And as you can see, missing fields, because for Tableau, this is a new field. So side by side, I'm going to go and add the sum of the current year of sales. And then I'm going to go and remove the missing fields. The same thing for the second one. We're going to go and add the differences and remove the missing field. And as well, we have to go and change the coloring again from red because it was a warning. And let's add it as black for the second one as well. Alright, so let's go and hit OK. So now as you can see, everything is back to normal and we have again our pan. Alright, so with that we have built our chart, and the next step is that we're going to go and format it in order to make it a beautiful chart, right? And this includes a lot of stuff like removing the lines, removing the grids, removing the headers, axes, adding coloring, simplify everything, right? So let's start with the easy stuff where we're going to go and remove those grids and those lines. So right click here on the empty space, go to format, and then we're going to go to the left side over here. Let's go to the lines. Let's check the 0 lines to none. Let's go to the rows, remove the grids as well. So now as you can see, we don't have any lines here in the middle. Let's go to the grids over here and let's go to the sheet and start removing everything. Like any line should be none. So with that, we are removing everything inside our grid. Alright, so now as you can see, we have cleaned up all those lines inside our charts and everything looks really clean. The next step is that we're going to go and work with the axis and headers. Let's go and remove the axis over here. So right click on it and let's remove the header. So now you might ask why we are removing a lot of stuff, and that's because in the dashboards, if you add a lot of informations, you're going to distract the users and they will not focus on the important stuff, which is showing the trends inside the view. So we have to reduce a lot of informations and only present the relevant informations. So really here we have to be very minimalist in the design. So now what is left is the months over here. So right click on that. Let's go to the edit axe. We want to remove the title from it. So let's go and remove that. And as well, we're going to go and indicate that those informations are months. So right click on that and format. And then let's go to the dates over here and let's have an abbreviate. So as you can see, now we have abbreviations of each month. Let's go and clear this. So now the goal is to show for the users this spark line is based on the months, and we don't want to show all those information. So it's enough to show only few values. So I would like now to show only January and December and remove all other information. So once you see it's January and December, you will immediately understand this is based on the months. So what we're going to do, we're going to go and edit the X again and change the axis. So let's go to the tick marks over here and let's go to fixed. And now next we're going to go and change the ticks. So it's going to start from January and it's going to show the value of December. So after the interval of 11 values, it's going to show the last month. So as you can see now, we are showing January and only December, and everything is between is not shown. So that's it. Let's go and close it. And as well, we have those nulls. Let's go and remove them. So right click and hide indicators. So now as you can see, we have everything cleaned up and we have only the line charts. And here we are indicating that it's based on the month. Of course, now what is left is the coloring of our charts. So as I said, I'm following here only 4 colors. So here we have our basic colors, but now let's go and change those informations. So now we're going to go and change the lines. Let's go to the lines over here and start working on the coloring. So edit colors. So now I would like to have the current year of sales to be very dark gray and the previous year gonna be like in the background as light gray. In order to do that, let's go and double click on the first value. So now what we're gonna do, we're gonna add our colors inside the custom colors over here in order to configure it only once and keep using it in all other charts. So let's start configuring the colors. Let's click on the first cell over here. So make sure you are selecting it. Then let's make it as something like here, very dark gray. And then the next we're gonna go and add to custom colors. So let's click on that. So with that, as you can see, we have defined the first color and let's go and hit OK. So with that, we have defined the first color. Let's go to the previous year sales and as well make a new color. So let's go to the cell over here beneath it and let's make it something like here. It's gonna be the light gray and let's make it more lighter. All right, something like this. Let's add to custom colors and hit OK. All right, so now let's go and hit OK. And with that, as you can see, the current year is going to be the black one or the very dark gray. And in the background, we have the previous year of sales. So now next, we're going to go and change the coloring of those 2 circles. So let's go to the min max and the marks over here. And let's grab the min max sales by holding Control and put it to the colors. All right, so now let's go to colors, edit colors. And now instead of automatic, let's go and switch it to custom over here, the last one. And then we're going to change the steps to only 2 steps. So now we're going to start on the right color where we're going to define the max value. So let's go inside and now we're going to define our third color. So let's click on empty cell over here and let's add the code of our third color, the turquoise. All right, then let's go and add to custom colors over here. So as you can see, we have our third color. Let's click OK. And now we have to define the left color. It's going to be the min value. So click on that and we're going to define our fourth color. So click on the empty cell over here. And let's add the code for the orange and then let's go and add it to custom colors. And with that, we got our 4 colors that we can use in all our charts inside these projects. So that's it. Let's hit OK and hit OK. And now as you can see, we got our 2 circles, the highest value, the min value using our coloring. And now the last touch that I'm going to add to this chart is to reduce the opacity of those 2 circles. So let's go to the colors over here and reduce it from 100 to something like 70%. So that's it. All right. So now the next step after formatting our charts, what we're going to do, we're going to go and work on the tooltip. So if you mouse over anywhere in the lines, you can see that we have a tooltip and it's not really nice. So as you can see, it looks like calculations and not human readable. So what we're going to do now, we're going to go and edit those informations. So now in order to do that, let's go to the tooltip over here in the marks and then we're going to get this box. So here we can see in this window, it's very similar like you are editing a title or any text in Tableau. So here you have 2 different types of text. The one that is not highlighted, this is going to be static, and the one that is highlighted with this light gray background, it's going to come from the charts. So now what we're going to do, we're going to go and remove all those informations and start creating our tooltip. So let's start with the first one, sales, and then we're going to have off, and then we're going to go and add the month. So we're going to go over here into insert, and then let's insert the month order date. And here we're going to go and add the current year. We can go and use, for example, the parameter for the selected year, but we're going to have a problem as we're going to show the sales of the previous year. So for that, in order to show the years inside the tooltip, we're going to go and create some calculated fields. So let's just close this and we're going to go back to it later. So now just check the tooltip. As you can see, we are going to get the sales of March, April, and so on. So we don't have a lot of informations, but now let's go and create a new calculated field. And now we're going to call it the current year. So it's going to be really simple. It's going to be the value that the user selected from the parameter. So that's it, select year. Let's hit OK. And now as you can see, we have the current year in the data pane. Let's go and create another one for the previous year. And it's going to be as well select year, but this time we're going to subtract 1 year from it. So that's it. Let's go and hit OK. But now I would like to go and change them to dimensions because they are not measures. So right click on the current year and let's change it to dimension, the same for the previous year. So let's go and convert both of them to dimensions. All right, so now we're going to go and grab all the information that we need in the tooltip to this box over here, to the tooltip. And as well the previous year, just drag and drop it on top of this box here. And let's go and show the information about the current sales and the previous sales and the differences between them. All right, so now we have all the information that we need for the tooltip. Let's go inside the tooltip and start configuring it. So let's go over here. And now after the month, what we're going to do, we're going to have a comma, and then let's mention the year. So it's going to be the current year, this one over here. All right, so after that, let's have double points and let's go and insert the current sales. So insert, and now make sure to select the current year of sales, this one over here, and not the fixed one. So it's like fixed, but now we would like to show in the tooltip the sales of the current month. So in order to do that, we're going to go and select the sum of the current year for the sales without any fixed. So let's go and select that. We're going to go and do the same stuff now for the previous year. So sales of, we're going to add again the month. So now we're going to go and do the same stuff for the previous year. So sales of, we're going to have again the month. So let's go and grab the month, comma, and then we're going to go and add the previous year. So it's going to be this one over here. So previous year, double points, and then let's go that gets the sales of the previous year. Okay, so now the next information, the next line going to be the sales differences. So let's say differences, then double points, and now let's go and add that differences. And here again, make sure to not use the fixed one that we have inside the title. Let's go and get the variable one. So the one that we added from the data pane. So this one. All right, the last information that we're going to show inside our tooltip is the min-max values. So the highest, lowest, sales, double points, and let's go and grab our measure. It's going to be the min-max sales. So let's go and select that. All right, so that's all the information that we want to add inside our tooltip. Let's go and hit OK and check the results. So for example, let's go to the blue point over here. So now we can see that the sales of the current year for the month November, it had this value, and as well it can be compared for the sales of the previous year for the same month. And then we can see the sales differences and what is the highest and lowest value. So now as you can see, as we are moving to different months, the values inside the tooltip gonna change. So now as you can see, the format and the design of our tooltip is not really nice, right? So for example, we have the thousands dots and as well everything bold, so it's not really easy to read. As well, the alignment of those informations are not really nice. So now we're gonna go and format it. All right, so now let's start first with formatting the current and the previous year. So let's go to the current year and let's have the default properties and then format number. We're gonna have it as custom. Let's reduce the decimal numbers and as well remove include thousand separator. All right, so now let's go and hit OK and let's just test. So now as you can see, 2023 don't have any dot. Let's go and do the same for the previous year. So let's go to the default properties and then number format, and as well let's go to the number custom, reduce the decimals and remove the thousand separator. So now the next one, what we're gonna do, we're gonna go and adjust the format of the numbers. As you can see, the current month has different format than the previous month. So now in order to do that, let's go to the previous sales over here, right click on it, and let's go again to the default properties, number format, and we're gonna go again to the number custom. Let's remove the decimals. The unit display is gonna be thousands, and we're gonna add the $sign. So let's go and add it and then hit OK. So now let's check again. So now we can see now both of the numbers have the same bar format. Let's check the max and min. You can see the max and min has as well the same problem. So let's go to the min max value, as well to the default properties, number format, and then let's go to the custom, remove decimals, add the $sign, and don't forget to add the unit. So it's gonna be the thousand. So let's go and hit OK. All right, so now all our numbers has exactly the same format. And now what we're gonna do, we're gonna go and format the text. So let's go back to the tooltip over here. All right, so now we're gonna go and work with two colors, the light and very dark gray. So let's select the first part where we have a text. We don't have a value. So this is gonna get the light gray. Let's take this value over here and let's remove the bold as well. All right, so now let's do the same for all other stuff. So we're gonna select the text, have the light gray, remove the bold, as well for the next informations. All right. So now for the next informations, as you can see, they have exactly the color that we need, and as well they are bold. So make sure that everything has a dark gray and as well as the bold. So everything so far is fine. Let's go and hit OK and test. So let's hover to this point over here. So now as you can see, it's really easy to read where we have a different coloring for the text and the value. All right, so now the last thing that we're going to do inside the tooltip is that we're going to change the alignment of the numbers. So as you can see, all those numbers starts from different positions. So now let's go and change the alignments. In order to do that, let's go again to the tooltip. So now what we're going to do, we're going to go and add a tab exactly after the double points and make sure there are no white spaces. So we're going to go over here to the first one. Let's add a tab. And now let's go to the second one. I believe we have here an empty space. So let's just remove it and add a tab. All right. So for the next one, I believe I have a space. So let's remove it and add a tab. And for the last one, the same thing. Remove the space and add a tab. The tab can go and automatically and do the alignment for all those numbers. So that's it. So we have all the tabs. Let's go and hit OK. And now let's go and test. So as you can see, all the numbers start from the same position. Let's go to the point over here as well. So as you can see, everything looks really nice. All right, so with that we are done and we added a very nice and readable tooltip inside our charts. So let's do a quick summary for the steps. First, we create our calculated fields that we need inside our charts and we do testing. Then the next step, we start building the chart. The third step, we start cleaning and adding format to the charts and the coloring as well. And the last step, we go and work on the tooltip. Perfect. So with that, we are done formatting the KPI of sales and everything look really beautiful. So now we're going to go and do exactly the same stuff twice, once for the profit and once for the quantity. So we're gonna do exactly the same stuff by creating the measures, creating the titles, and then the spark line. So now what you're gonna do, you're gonna pause the video and start creating those two KPIs, exactly following the same stuff, starting by creating the calculated field for the current year of the profits and ending up by having something very similar to here, but instead of total sales, you should have the numbers from the profits. So I'm gonna go and do it offline and then we're gonna meet.
2 hours later.
All right, so that was a lot of calculations and a lot of stuff, but exactly the same steps. So I hope with that you are done building the other two KPIs. So now we have a KPI for profits, for quantity, and as well for sales, and all of them looks like really similar. Alright, so now we are halfway there. We are done with the first two requirements. Then the second two requirements is to build the charts about the subcategories and the weekly trends. So now let's start with the first one, the subcategory comparison. So what we're going to do, we're going to go and compare the current year and the previous year of sales by that subcategory. And as well, we're going to go and add the profit informations. And we have decided in the mockup to use bar in bar charts for the sales of the current and previous year, and as well another separated bar chart for the profits. Alright, so now let's go in Tableau and create these charts. Let's go and create a new worksheet. Let's call it subcategory comparison. Alright, so now the first step is that we're going to go and ask ourselves, do we have all the data that we need for this chart? Or do we have to create any calculated fields? I think for these charts, we are safe. We have almost everything. So this is what usually happens in the projects. For the first chart, you're going to end up creating a lot of calculated fields. But as you are creating views and charts, you will have less need of creating new calculated fields. So now let's go immediately and start building our charts. Let's go and get our subcategory. So we're going to go to the products over here, drag and drop it to the rows, and then we need the two measures, the previous year and the current year. So let's start with the previous year of sales. Let's drop it to the columns. So this is going to be the first bar where we have it in the background. Now let's go and get the second bar for the current year of sales. So drag and drop it to the view over here. So now what we're going to do, we're going to go and bring them together in one chart on top of each other's. But before that, I would like and go and format it a little bit so that immediately we're going to get the bar in bar chart. So what we're going to do, we're going to go to the second tab here in the marks, and let's go and make the size smaller. And now next we're going to go and change the color as well. So let's go to the color over here and let's go to more colors in order to get our colors right. So let's get the dark one and hit OK. And next what I'm going to do, instead of automatic, I'm going to make it bar in order to make sure that once we merge everything, it stays as bar and doesn't break. So now let's go to the background, to the left one, and format it as well. So let's go to the colors, more options, and now we're going to get the light gray. So let's select that and hit OK. Alright, and as well, we're going to make sure that it is a bar chart. Alright, so with that, we have got the background and the front. Let's go and merge them, right? So let's go to the current year of sales, right click on it, and let's use the dual axis. Great, now we have bar in bar, but as usual, we have to go and synchronize them. So right click on the current year of sales, synchronize axis, and as usual, we're gonna go and hide it. So right click on it and hide the header. Alright, so with that, we have the bar in bar chart. We will go and format it later, don't worry about the look and feeling of these charts. Let's go and add the profit now, right? So let's go and grab the current year of profits and drag and drop it to the columns as well. So as you can see, it's really easy, right? We got now a second chart for the profit side by side to the sales. So now the next thing that I'm gonna go and show the parameter as well in order to test it. So let's go and show parameter, and now let's go and change the year, for example, to 2022, and see that everything is changing. So everything is working as intended. So let's go back to 2023. All right, so that's it. We have created the charts. It's really easy working with bar charts compared to the KPIs, right? So now let's go to the next step where we're gonna go and start cleaning, formatting, changing the color, changing the sizes. So let's go and do that. So first, let's go and hide all the lines inside our grid. So right click on the empty space, go to format. Let's go first to the lines and check what do we have over here. So make sure to have the 0 line away, rows, columns. So let's go and remove the columns as well. So that's it for the line. Let's go and switch to the borders or to the grid, and let's go to the sheet over here and start removing everything. So we don't need any lines. So that's it. Now our chart is really clean and we don't have any lines. Next, we're gonna go and start hiding the axis and some informations in the headers. So let's go to the axis over here and remove the header. And as well, we can go to the headers informations over here, but we want to just hide the title, the subcategories. So right click on it and then hide the label. So with that, we removed it. We don't need it because we have it in the title later. Alright, so now the next step is that we're going to go and start formatting the coloring and the fonts and so on. So now let's go to those informations to the subcategory, right click on it and let's go to format. And now let's go to the font over here. Let's make it dark, and as well let's go change the font to a medium, Tableau medium, and let's make it 10. So in order to make it more clean. Alright, so that's all for this information. Now let's go and start formatting the charts. So now what we're going to do first, let's go and change the sizing of those bars on the left side. So let's go to the previous sales. It's going to be the background. Let's make it a little bit bigger. And then let's go to the front one, to the current year, and make it thinner. So let's go to the size over here and just make it smaller in order to see the effect of bar and bar. Alright, so this is way better than before. So that's it. And of course, here's the coloring is working because we changed that before. But now what we're gonna do, we're gonna go and change the coloring of the profit. So let's go to the current profit. And what we're gonna do, we're gonna add the measure to the color. So hold Control and drag and drop the profit on the colors. Alright, so now let's go and edit those colors. Now what we're gonna do, we're gonna go and change the steps to 2 steps, and let's change the positive and the negative values. So the positive one, we're gonna use our color over here, the turquoise, and then for the lower value, we're gonna use the orange. So let's go and change that. So that's it. Let's go and hit OK. And with that, we can immediately identify which subcategories has a positive profits and which one has a negative one. Alright, so now we are done with this step where we have cleaned and format everything inside these charts. But now before we go to the next step where we're going to work with the tooltip, I would like to add here a KPI to indicate where do we have an issue. That means I'm going to show an icon when the current year is less than the previous year. So in order to do that, we're going to go and create the KPI. Let's go and create a new calculated field. Let's call it KPI current year less than previous year. So now it's really easy. If the current year is less than the previous year for the sales, we're going to show an icon. So in order to do that, we're going to use the condition. So if, and we're going to check the sum of the current year of sales is smaller than the sum of the previous year for sales. So what can happen? We're going to go and show an icon. So we're going to say then, and we're going to add the circle. And now, of course, the question is how to copy the circle. I'm going to leave this calculation in the description for you to copy and paste. So now, what can happen if the condition is not fulfilled? So we're going to say else is just empty. So that's it. Let's end it. So the calculation is valid. Let's go and hit OK. And now what we're going to do, we're going to grab this new calculated field and just put it in front of the subcategory. So now we can see immediately where we have bad performance for the sales. We have 3 categories with these 3 circles. So now let's go and format it. I'm just going to grab the bars and put it side by side to those circles. And then we're going to go and change the colors as well. So right click on the circle. Let's go to format. And then let's go to the font over here. Let's go to more colors. And we're going to go and get the orange since it is always like a loss. So let's go and hit OK. So of course we can go and test stuff. Let's go and change the year to 2022. So we have here again different subcategories with issues. And let's go to 2021. And here we can see we have a lot of subcategories where the current year is less than the previous year. Alright, so as you can see, it's really nice KPI in order to show immediately where do we have any issues. So now let's go and switch it to 2023. And with that, we have our KPI. But now I would like to go and sort the data in order to have it as a rank. So let's go to the subcategory over here and let's go to sort. And then let's go and switch it to a field. And we're going to choose the field to be the current year of the sales, and let's have it as descending, so we have like a rank. All right, perfect. Let's go and close it. All right, so that's it. I'm really happy with the view. Let's go now to the last step where we can adjust the tooltip. Okay, so as first step, let's go and add few informations to our tooltip. So what we're going to do, we're going to go and grab the previous year of sales. So by holding control, put it in tooltip, the current year and the profits. And then we're going to go and grab our current year and the previous year. And as well, let's go and add the differences between sales to the tooltip as well. All right, so now let's go inside and start configuring those stuff. So let's check. The first one going to stay as it is, so the subcategory. Then let's have next the current sales. So I'm just gonna cut it and paste it over here. But I would like to go and change the text. So it's gonna be sales of, and then we have to go and insert the year, right? So the current year, and then we're gonna add the double points and make sure to remove the space and add a tab. All right, so the next line gonna be about the previous year. So I'm just gonna cut and paste and then change the text to sales of, and let's go and insert the previous year. So let's just make sure that we have a tab after the double points. Perfect. And then let's go and add the differences. So let's go and get the differences over here. It looks nice. I'm going to leave it as it is. And then the last info, I'm going to go and add the profit. So we're going to add the profit over here. So profits of, and then let's go and add the year, the current one. So the profit of the current year, it's going to be the sum of the current year of profit. So let's make sure that we have the tab. So that's it. Let's go and remove everything else. And with the coloring, everything looks fine. Let's go and hit OK. So now let's go and test it. And now we can see everything like formatted really nicely. So the subcategory is machines, the sales of the 2023, 2022, the differences between them, and the profits. And you will get as well the same informations if you go over here to the right side to the profits. So now the last thing that I'm going to change is the format of that 2023 for the sales. So let's go and change that. Right click on it, and then let's go to format, the usual stuff. We're going to go to the number, to the custom, remove the decimals, add the units, and then the prefix of $sign. So that's it. So now let's go and test it. And with that, you can see the numbers of sales and profits follow exactly the same format. So that's it for the tooltip and the last step for this chart. Now everything looks really professional. So with that, we have completed the third requirement for this dashboard, where we compare the sales and profit informations by the subcategory. Alright, so now we're going to move to the last requirement, to the last chart for our dashboard. We're going to create a line chart in order to show the weekly trends for sales and profit. And as well, we have to show the average line for both sales and profit. And we have to highlight what is above the line and below the line. So let's go and create a new worksheet. So we're going to call it the weekly trends. Alright, so now the first step, do we have all the data that we need in order to build the chart? Well, yes, we have the current year for the profit and for the sales. Then that means we can now go and jump immediately building our charts. So since it is a weekly trends, we need the order date. So let's go and get the order date, put it to the columns, and now let's change it from year to weeks. So right click on it. Let's go over here to the more and then week number. But we would like to get a continuous line. It's always better than a discrete line. So right click on the weeks over here and let's switch it from discrete to continuous. All right, so with that, we got the number of the weeks. And now let's go and get our measures. So the first one gonna be the current year for the sales, and the next one gonna be the current year for the profits. And with that, our view is split into two charts, one for the sales and one for the profits. And with that, we can see the weekly sales and the weekly profits. All right, the next step is that we're gonna go and add the reference line for each measure. So let's start with the sales, right click on it, and let's go and add a reference line. So here we have everything prepared, everything is fine, average of the sales. I'm gonna go and change the label from computation to custom, and let's add the following. So average, and then space, and now let's go and add a value. And that's it for now. So with that, we have a really nice average line inside our chart for the sales. Let's go and do the same for the profit. So right click over here, add a reference line. So now the value is the profit and the calculation is average. Let's go and change the label to the same stuff. So average and then space. Let's go and insert the value, and that's it. Let's go and hit OK. So with that, we have fulfilled the two requirements. First, we have the trends for both of the sales and the profit, and we have an average line for both of the measures. Now you might ask why we don't go and merge those two charts in one using the dual axis. Well, I would do that if we don't have average lines. So imagine now we merge both of them and then we will get two average lines. It's going to be really hard to read the charts. So for this scenario, since we are focusing on the average, it doesn't make sense to merge them together. Then it's going to be really hard to read. So that means for these requirements, we're going to leave them separated from each others. Well, that's it for building the charts. It's really easy, right? So now we're going to go to the fun part, to the next step where we're going to start cleaning, formatting, adding colors. So let's start doing that. We're gonna start by removing the lines. So right click on the middle, let's go to format. And now first we start with the lines. So let's remove any lines inside the sheets, inside the rows, and the columns. Alright, but this time we will not go to the grid and remove any lines because they are really important in order to separate both of those charts. So we will not touch anything here. So only the lines and not the borders. Alright, so that's all about cleaning up the lines. Let's go now and clean up and format our axes and headers. So let's start with the weeks over here. What I'm gonna do, I'm gonna go and just remove the title. So let's go over here, remove the title, in order to have more space. Alright, so now let's go and format those axes. I will just change the title to only sales. So let's remove the first part. The same thing for the profits. Let's just have only profits. So that's it. And now we still have an issue. We have different formats for the numbers. So as you can see, we have here the $sign, and on the sales we don't have it. So let's go and format it this time from the data pane. So right click on the current year of sales. Let's go to the default properties, number formats. As usual, we can remove the decimals, add the unit, and add the $sign. So that's it, hit OK. Now as you can see, we have exactly the same format and as well for the average. Alright, so that's it for the axes and headers. Let's go and now format the reference line. So right click on the reference line, let's go to format. And now what we're going to do, we're going to change the line to a dashed line and as well increase the opacity to around 30%. Alright, and as well let's change the color of the font to make it a little bit darker. Okay, so that's it for the first one. Let's do the same stuff for the second average line. Right click on it, go to format, change it to dash, and let's increase the opacity, so around 40%. And the font, let's make it darker. Alright, so with that we have formatted both of those average lines. So with that we have formatted everything around our chart. So now we're gonna go and start formatting our line charts. So now what we can do for those lines, we can change it from linear to steps in order to make it more interesting. So what we're gonna do, we're gonna go to all, and then let's go to path, and then instead of having the linear, let's go to the steps. So now as you can see, our chart's gonna look more interesting than the boring linear. So now let's talk about the coloring of those two charts, because we have a requirement that says we have to highlight the weeks that's above the average and as well the below average. So we're gonna use the coloring in order to do the highlights. And now we might say it's really easy. Let's go to the colors for example, to the sales. Let's hold Control and put the colors over here. Well, you can do that, but it's not really 100% correct, because you can see we have the light colors below the average and we still have here as well a light color above the average. So in order to be more precise, we have to go and create calculated field for the coloring. So let's go and do that first for the sales. Let's go and create a new calculated field. We're gonna call it KPI sales average, and for this calculation we want only two values as an output. Either it is above the line or below the line. So in order to do that, we have to go and check that using the if-else statements. So let's start with the if statements, and let's say if the sum of sales of the current year for the sales is higher than the average. So let's say higher. And now in order to check the average for the weeks, what we're gonna do, we're gonna use the window average function, and then inside it we're gonna have our aggregated field, the sum of current year for the sales. So now what we are doing over here, we are just checking whether the sales is higher than the average sales. But we are using the window function because we care only about this window, this year. So we don't want to have the average of all other years. We are just focusing on the window that we have inside our chart. So what can happen if the condition is fulfilled? So let's have then, we're gonna have the value above. Otherwise, we're gonna have the value below. So that's it. Let's end it. So with that, the calculation is valid. Let's go and hit OK. And with that, we got our new dimension. Let's now and move it to the colors instead of the sum of sales. So now we can see immediately that anything below the average has the color of orange, and anything above the average has the color of blue. So let's go and change the coloring to our colors. Let's go and edit the colors. And now let's go to above, double click on it. Let's have our blue or turquoise. Then let's go to the below and get our second color. So that's it. Let's hit OK. Perfect. So now we have it. We are highlighting what is above and what is below the average. Let's go and do the same stuff for the profits. So what I'm going to do, I'm just going to go and duplicate the same calculation, and then let's go and edit it. So now we're going to go and replace the sales with the profits. So let's start with the title, profits. Let's remove the copy. Let's have the current year of the profit, and as well here, the current year of profit as well. So everything is fine. So as you can see, we are doing exactly the same stuff, but only for the profits. Let's go and hit OK. And then what we're going to do, we're going to go switch to the profit in the marks, and let's grab our new calculated field to the colors. So let's go and do that. And the next step, we're going to go and change the coloring. So edit colors. The above going to be the turquoise, and the below going to be the orange. So that's it, let's hit OK. Alright, so with that we are as well highlighting the stuff in the profit above and below the line, and with that we have covered all the requirements for these charts. But now as usual, don't forget always to test, so let's go and select the years and show it to the parameter to the right side, and we can start testing the other years whether everything is fine. So as you can see, everything is nice. Now we're gonna go to the last step where we're gonna add the tooltips. So what we're gonna do, we're gonna go to the all over here and let's add the current year information to the tooltip. We don't need the previous year because here we are not comparing the current and the previous. So now let's go to the tooltip and check what do we have over here. I think we have almost everything that we need. So now let's go and change a little bit stuff. So instead of week of order date, let's have the number of week. And as well, let's just make sure that we have a tab after the double points. And then the next one, we don't need it. So now the next one, we're going to have the current year for the sales. I'm just going to go and rename it sales of, and now let's go and insert the current year. And as well, make sure that we have a tab after the double points. Then the next one is going to say whether it is above or below the average. So what we're going to do, we're going to remove this part over here and we're going to have above or below. And after that, we're going to add the static word, the average. So since it's static, let's go and format it. So let's remove the bold and make it light gray. Okay, so now let's go and do the same stuff for the profit. So instead of the current year of profit, we're going to say profit of, let's go and add the current year, then double points, make sure there is no spaces, and then a tab. And the same stuff for the average KPI. So we're going to say the average, and as well format it. Alright, so I think this is nice. Let's go and test it. So let's go and hit OK. Alright, so now let's go and test. If I check any value above the average for sales, we can see that the number of week, the sales of 2023, and it says it is above the average. So if we go below the average, we will get below the average. So as you can see, everything is working perfectly. Let's go to the profits. So we have above the average over here, and we got the profit of 2023. And if we go below the average, and we can see it is below the average, everything is perfect. And with that, we have covered the last chart inside our requirements. So that means we have now all the sheets that we need for the dashboard. So the next step that we're going to go and start building the dashboard. Alright, so now we're going to start talking about building the dashboards. The first step is that we have to plan the structure and the containers of our dashboard. Alright, so now let's start sketching the container structure. The first one is, as usual, going to be the main container, and it's going to be a vertical container. And then we're going to start from top to bottom. So first we have like a title and two buttons. So for that, we can include a horizontal container where we have the title and the buttons. Moving on below that, we have the information of the KPIs. So we have side-by-side objects. Here again, we're going to go and use another container, another horizontal container, in order to have all those KPIs side by side. Then moving on below that, we have the charts, right? So it's again two charts side by side, and we will use a third horizontal container for them. So this is the main object that we have inside the main vertical container. But of course, in our dashboards, we have as well a lot of filters. So what we're going to do, we're going to build a vertical container where we're going to put all the filters for the dashboards. But this container is going to be outside of the main vertical container, and we will use the floating options. And this vertical container is going to be outside of the main container, the vertical container. And for that, we're going to use the option of floating and as well the ability to hide it or show it. So I would say we will go with this plan, and of course it is a plan. So that means as we are building the dashboard, sometimes we add like an extra container to organize stuff. So we will not cover everything in the plan 100%, but we will cover the main stuff. Alright, so now with that we have a plan for our dashboards. Let's go and implement it in Tableau. Alright, so now let's go and create a new dashboard, and we're gonna call it sales dashboard. So now the first step that I usually do is fixing the size. So let's go on the left side to the size, change it from range to fixed size, and then let's go to the width. I usually go with the 1200, and for the height, let's go for 800. Okay, so with that we got enough white space for our dashboard. And I usually start with the main container, but since we have another container which is going to be hidden and shown for the filters, I'm going to start with that first. So now in order to create this vertical container, I have a quick way in order to catch it. So what we're going to do, we're going to take any worksheet. Let's for example go with the KPI sales. Let's drag and drop it to the middle. So as you can see, Tableau can go and automatically create a vertical container on the right side where it's going to put everything inside it, the parameters, filters, legends, and so on. And this is the container that we're going to use for our filters. So now what we're going to do, we're going to go and convert it to a floating element or floating container. So in order to do that, hold shift and then click on this icon over here and then just move it. So as you can see now, it's like freed, and let's drop it anywhere. So now let's just move it here to the end. And what we're gonna do, we're gonna go and remove this chart because we have to go now and build the main container. So let's go and just remove it. And as you can see, we still have it here on the right side. So now what we're gonna do, we're gonna go and color the container. So make sure to select the container over here. Let's go to the layout, and then let's go to the border, make it a line, and then let's choose any color, for example, the purple one. And as well, let's go and put a background for it. Maybe the purple as well. So with that, we can see that we have here a container, a floating container on the right side. And the next step, we're going to go and give it a name. So we have it here in the item hierarchy. Let's go to the vertical container, click on it, and then let's give it the name of filter. So container filter. Alright, so now we have our first container. Let's go back and start building the main container for the dashboards. So let's go back to the dashboards and let's grab a vertical container for the main one. So let's drop it here in the middle, and now we're gonna go and add the coloring for it. So let's go to the layout, let's go to the borders, and let's have it as an orange. And as well, I would like to add a background color for that. So let's take the orange as well. So with that, we have our main container. On the left side, you can see we have the tilde and then the vertical container. Let's go and rename it. I'm just gonna make it a little bit bigger over here. So we're gonna say you are the main container. Alright, so now the next step is that we're gonna go and add blanks in order to have a placeholder for the elements inside this container. So let's just go and add one, and then let's go with the first container inside the main one. We have the horizontal container for the title. So let's take a horizontal container, just drag and drop it here below. Make sure that is inside the main container. So do that carefully. Alright, so we have our horizontal container. Let's go and put some coloring on it. Layout, border, and let's make it blue. And as well for the background, let's have it as well as blue. So now of course, let's go and check stuff over here. So we have the vertical container, we have our blank on top, and then we have the horizontal container. Let's go and rename it. You are the container for the title. Alright, so now let's go inside it and put some content. So what we have a text. So let's drag and drop it inside the horizontal container. So let's say you are the sales dashboard. We will format everything later. So that's it. Let's go and hit OK. So now as you can see, our container can be very small. Let's make it a little bit bigger. And now we have to go and add the two buttons. So let's go with the navigations. Make sure to add it inside to the right side, right? Because it is horizontal container. So let's go and drop it, and we need another one. So let's go and drop it as well to the right side or in the middle, doesn't matter. Alright, so now let's go quickly and check the layout to make sure that everything is fine. So inside the title, we have a text and then two buttons. Great. So now let's go to the next content. We're gonna have another container for the KPIs. So let's go again to the dashboard and take horizontal container and make sure to put it beneath the first container. So let's drop it over here, and now make sure to click it, and let's go and add the coloring to it. So it's gonna be line and as well blue. The background gonna be as well blue. Alright, so now the next step, we're gonna go and add again a name for it. So let's go inside. You are the container for the KPIs. Okay, so now let's go and add some content inside it using the blanks. So the first blank, make sure to drop it in the second horizontal container. And now we have it very small. So let's go and extend it. And then let's grab another one. Make sure to put it on the right side. So now with that, we have two blanks, and let's go and grab the third one to the right side. So with that, we have our three placeholders for the KPIs. And again, I always go back to the layout to check that everything is fine. So as you can see, the three planks are inside the KPI, so everything is clean. Let's go back now to the dashboard and add the last container for the charts. So we're gonna go and grab again a horizontal container, drop it below the middle one, and let's go and add some coloring to it. So let's go to the layout, we add some border, blue, and as well a background for that. Now let's go and give it a name. So you are the container for the charts. Okay, so now let's go and add some blanks in order to have some content inside it. So the first blank inside it, and now we have it very small, so let's extend it, and the second blank to the right side. So now we have two places for our charts. Let's go to the layout and check. As you can see, we have the two blanks underneath the charts. Alright, so with that we have the 3 containers for our content. Let's go and remove the first blank since we don't need it anymore. So we have it in the top over here. Let's go and drop it. So with that we have built the foundation, the structure of our dashboard. So we have the container for the title, we have the 3 KPIs and then place for the 2 charts. And as well we have here on the right side our floating container for the filters. Alright, so as you can see it's really easy. Just do it slowly, step by step, check everything, give it a name, don't rush it. Alright, so that's all for this step. Now finally let's go to the step where we're gonna put everything together and put the content inside our dashboard. Okay, so now let's go and put all our content inside our dashboards. Don't worry about the filters, we're gonna do it at the end. So let's start with the KPIs, right? So we're gonna take the first one, the KPI of sales, make sure to put it near the blanks, and then let's go and grab the second one next to it, and the quantity as well next to it. So let's go to the layout to check everything. So as you can see, we have this container for the KPIs, and inside it we have our 3 KPIs. Now we don't need anymore the blanks. Let's go and start deleting them. Alright, so now let's keep going and put the other charts inside our dashboards. Let's take the subcategory, make sure to be inside the 3rd horizontal container. So let's drop it over here. And then the last chart is going to be the weekly trend. Let's drop it side by side over here. So let's go to the layouts and check. So as you can see, the horizontal container for the charts has our 2 charts and the 2 blanks. Let's go and remove the blanks. Great, so now you can check again our structure in the item hierarchy to see that everything should be looking like this. So we have the main container where we have inside it 3 horizontal containers. The title should has the title and the 2 buttons, and then the KPI should has the 3 KPIs, and the chart should has the 2 charts. So if you have it like this, that means everything so far is clean and we are on a good way. Alright guys, so that's it for this step. We have the main content inside our dashboard and it was very easy and fast. So now in the next step, things gonna get interesting where we can start formatting, coloring, positioning the stuff in order to have a clean and professional dashboard. Okay, so now let's start formatting our dashboard. The first step is that we're gonna go and make sure that our content is distributed evenly in each container. So let's go to the KPI container over here, make sure to select it, and let's go to this small arrow and let's click on distribute contents evenly. Alright, so let's move to the next one. As you can see, those 2 charts are not distributed evenly. So let's select the container and let's go to the more options and distribute it evenly. So with that, we're gonna get a fair alignment for all charts. We will not do that for the first container because the title should be bigger than the navigation buttons. Okay, so now let's start from top to bottom. Let's start with the title. So let's go inside the title over here and start formatting it. So we're gonna call it sales dashboards. And then let's have a pipeline, and then let's have the year, the current year that the user selects. So what we're gonna do, we're gonna go to insert and let's add our parameter. So now let's go and change the font size. Let's select everything and make it, for example, 24. And now let's go and change the coloring. So let's go to the colors and pick our coloring, right? So let's go and pick the dark one. And for the year, let's have it as Tableau medium and pick the other color, the turquoise. Alright, so with that we have our title. Let's hit OK and check how it looks like. Yeah, I think it looks fine. Let's make it a little bit smaller. Okay, so that's all for those 2 containers. Now let's go and check the buttons. We have to make sure that those buttons has exactly the same sizing, which is really hard to configure. So what we're gonna do, we're gonna go and grab a mini horizontal container in order to put those 2 buttons inside it and distribute it evenly. So with that, we're gonna get a perfect sizing. Let's go to the dashboard and let's get a horizontal container. Make sure to drop it to the right side. So with that, we have a small container. Let's make it a little bit bigger to see it. I'm just gonna remove stuff. And now we're gonna go and move those buttons inside it. So let's drop it inside it. And as well, pick the second one and put it to the right side. So now, of course, let's go quickly and check that everything is fine. So now let me close all those stuff. We are at the title, we have our title, and then we have the mini horizontal container, and inside it we have the 2 buttons. Alright, great. So now let's go and make everything distributed evenly. So let's go to the horizontal container. Let me just quickly give it a name. So you are the horizontal container for the buttons. Okay, perfect. And let's go and distribute this container evenly. So make sure to select the horizontal container. And let's go to the options and distribute content evenly. So now as you can see, those 2 buttons gonna get exactly the same size. So as I'm reducing or making it bigger, both of them gonna get exactly the same size. So let's just make it a little bit smaller. And now let's go and change the design of those buttons. So click on the first one. Let's edit the button. Okay, so now let's say the first button gonna be for the sales dashboard. So let's go and select it. It's gonna be the sales dashboard. And now let's go and give it a title or a name. It's gonna be sales dashboard. And now let's go and format the font. It's gonna be white, so everything is fine. Let's go to the background. Let's pick our colors. So let's go to more colors and pick our blue. Okay, so what else? Let's go again to the fonts and make it, instead of 12, let's make it like around 10. All right, so that's it. Let's go and hit OK. Now with that, we have configured the first button. Let's go to the second one. Let's go and edit the button. And now since we still don't have this customer dashboard, we cannot go and select it, but I want to format it. So let's go to the font, make it 10, and this time I'm gonna make it black. And let's give it a title. It's gonna be the customer dashboard. And for the background, it's gonna be the white. And let's go and add a border for it. So it's gonna be the line, something like this maybe. And then a gray. Okay, so now let's add a tooltip. It's gonna be go to customer dashboard. Okay, so let's check that. Okay, so as you can see, we got the second button. It's still gray because we haven't selected any dashboard. So once we have a dashboard, it's gonna be white. So now let's go and make it a little bit bigger. So select the container, just make it a little bit bigger. Okay, so that's it. We will visit it later once we have the customer dashboard. All right, so that's all for now for the first container. What I'm gonna do, I'm just gonna go and remove the background coloring of the container. So let's select the title. Let's remove the border and as well the background color. So let's have it as none. All right, so now let's move to the next one. We have our KPIs. So the first thing that I'm gonna do, I'm just gonna make it a little bit bigger, maybe to the middle, somewhere like this. And then what we're gonna do, we're gonna go and add the background color. So as you can see, we have here a white color, but here we don't have any coloring for the title. So in order to do that, let's click on each one of them. And then we go to the background. Let's make it white. Then to the next one, white, and the third one, it's gonna be as well white. Okay, so now we have like a big card or big KPI for all those informations for each one of them. All right, so now the next step is that we're gonna go and remove the coloring of this container. So let's remove the border and remove as well the background. All right, so now let's start with the first container over here. What I'm gonna do, I will just as well add a background color for those two charts. Gonna be the white. And now what we're gonna do in order to configure those stuff, we still have this container which is really bothering me. So let's go and select the whole container. Let's move it to the top over here, and then let's go to more options, and we're gonna select this one, add show hidden button. So let's click on that. So once you do that, you will get like small icon in order to show and hide the whole container. So what we're gonna do, we're gonna hide it. So click again on the options and hide it. So now the whole container is inside this icon. I will just place it over here in order to work on our charts. All right, so now the next step that I would like to go in each chart and make sure that it fits the entire view. So let's go to the first one. You can check it from here. You can see it is entire view. The next one as well, third one, and as you can see, it's standard, so let's go and switch it to entire view. And the same thing for the weekly trends, it is entire view. So with that, we make sure that Tableau is using the whole space, and we can make this one a little bit bigger. And as well as you can see, we still have a little bit space. So let's go to the middle over here and make the KPIs a little bit bigger in order to use the whole white space. All right, so with that, we have a perfect positioning for each chart. I'm really happy with that. All right, so now the next step is that we're gonna go and add some nice legends to our charts. So now for the first chart, we have to give the following information for the users. So the dark gray gonna be the current year, and the background color is the previous year. So now I'm gonna go and customize a nice legend. I will not use the one that's from Tableau because I want to customize it. So for that, we're gonna go and create quickly a chart for the legend. So let's create a new sheet, and all what we need is the text of the current year and the previous year. So we have it as calculated field. So let's move the current year to the text and as well the previous year to the text. So now let's go and customize those informations. Okay, so now we're gonna start on the left side. So let's make the alignment to the left. I'm gonna start with the first information, the current year. So we're gonna say the current year sales. Let's make the S bigger. And let's go and change the font to something like maybe a medium. And as well the coloring, it should follow the pattern in the chart. So the current year of sales, it was a dark one. So let's go and pick our dark color. And for the previous year, it was the light color. So let's do that, and let's make the current year as bold. Okay, so let's go and test it. Let's go and apply. Now Tableau going to show it as hashes because the size is really small. So let's go and hit OK. And we can go to the standards and make it entire view. So now we can see it over here, 2023 sales versus 2022 sales. So now as you can see it, the current year versus the previous year. Okay, one thing that I'm not really happy about it, let's go inside it and remove the bold. Okay, and let's give it a name. So this is going to be the legend of subcategory charts. So that's it. Now let's go to the back to the dashboard in order to use it. Now I would like to have the legend between the title and the charts. We cannot do that. So instead of that, we're going to go and make an extra container for those three informations. So we have a title, a legend, and then the charts. So as I said again, we cannot plan everything at the start. As you are building the dashboard, you will understand the needs and you will adjust stuff. So now what we're going to do, instead of having these charts, we're going to have a vertical container inside the horizontal container. So now let's grab a vertical container, and the best thing to do it here in the middle. And what we're going to do, we're going to grab the chart and put it inside this container. So make sure to drop it inside this container. And of course, let's go quickly and check the layout whether everything is fine. So it's inside the tilted, main, charts. So now instead of the first charts, we have a vertical container. So let's go and give it a name quickly. So you are the container of, let's say, chart 1. And inside it, you can see we have our charts. So now our vertical container is going to start with a title. So let's go and grab a title or a text on top. And now we're going to give it the name sales and profit by subcategory. So now let's go and format it. You're going to be Tableau medium as a font, and then the size going to be 14, and the coloring going to be the dark one. So let's go and select that. Okay, so that's it. Hit OK. All right, so that means we don't need the title of our chart. Right click on it and hide the title. Great. So now finally we can go and grab the legends. But now in this chart, I would like to have as well a legend on the right side for the profit. So that means we have a legend on the left and legend on the right. And in order to do that, we're going to have another container in order to put those two legends side by side. We cannot do it currently because we have a vertical container. So let's go and grab a horizontal container and just put it in the middle over here. You just resize it. So make sure to select the container and let's put the first legend inside it. Okay, so now we have a title for this small legend. Let's go and hide it. Great. So now let's go and make everything smaller. All right, so with that, we have a really nice legend where we are telling the users we are comparing the sales of 2023 with 2022. All right, so now let's go and configure the right legend. We have to tell the users this is profit informations, and the blue color indicate for profits, the orange gonna indicate for a loss. So for this legend, I'm just gonna use that text object. So let's drag the text and make sure to put it inside this mini container to the right side. So first, let's indicate the current year. Let's go to insert and have the parameter, because here we have the profit only for the current year. So next we're gonna say, okay, a circle, this is gonna be profits, and another circle, this is gonna be loss. Okay, so now let's go and make sure that the font is a Tableau medium. It's going to be in 9, and let's go and make sure that the coloring that is used is the dark one. But now let's go and change the coloring of the circles. So the first one going to be the blue, and the loss is orange. So our orange. Okay, so now let's go and hit OK and test it. All right, so now as you can see, we have it really big. Let's go and make it smaller. All right, so with this legend, the users can see immediately that we are talking about 2023. The blue one can be the profit, and the loss is going to be the orange. All right, so now I'm really happy with the first chart. Of course, we still have the coloring of the background. Let's go to the layout and make sure that everything is correct of the containers. So let's go to the chart one. As you can see, we have a vertical container, we have a text, and then we have a horizontal container for both of the legends. So inside it, you can see we have the chart for the first legend and the text of the second. And then below that, we have our chart. So if you have it like this, you are following me correctly. Now what we're going to do, we're going to go and give a background color for the whole container for the first charts. So let's go to the background over here and make it as a white. So with that, the user is going to get the feeling that everything is in one unit, in one chart. All right, so this is for the first chart. Let's go and do the same stuff for the right one. So in order to do that, let's go and grab a vertical container and let's grab it to the middle over here. So now with that, we have our container. Let's go and grab our chart and put it in the container, the new one that we have created. So now with that, we have our chart inside the new container. Let's go and check the layout to make sure that everything is fine. So let's go to the charts. We have chart 1 and the new one can be for the chart 2. Let's go and rename it. So you are the container for chart 2. Okay, and inside it we have our chart. So perfect. So that means we're gonna go and grab a text object and drop it on top of our chart inside the new container. So let's call it sales and profits trends over time. Now we're gonna go and start formatting it. So let's go and grab the Tableau medium, and as well it's gonna be 14. Let's go and pick our color. It's gonna be the dark one. So with that, we're gonna get exactly the same title as the left one. Okay, so the next step, let's go and hide the old title from the charts. And next we're gonna go and put our legend. So it's gonna be a text object. Let's put it in the middle between the title and the charts. So now what we're gonna say in the legends, let's enter a parameter in order to show the year. And after that, we're gonna have a circle and we're gonna say this is the above, and another one is gonna be below. So now with that, we're going to indicate whether the line is above the average or the below the average. And we are using the coloring. So the above is going to be the blue one. Let's go and choose that. And below is going to be the orange. Our orange color. Now what we can do, we're going to make sure that we are following the same font. So it's going to be the Tableau medium. And it is a 9. Alright, so that's all. Let's go and hit OK. I think we missed out the coloring of the 2023. Let's go inside it and make sure to choose the dark color for it. All right, let's hit OK. So now we got a quick explanation about the coloring inside our chart on the right side. So now what we're going to do, we're going to go and select the whole container, and we're going to change the background color to white in order to have this one unit feeling in the chart. So let's go to layout, and let's go to the background and choose the white color. All right, so with that, we are done with the container of charts. And what we're gonna do, we're gonna go and select the whole container and remove the border and as well the background color. Okay, so now by looking to our charts inside our dashboards, we still are missing some information about the KPIs. We have to present here a legend explaining those 2 points and as well the coloring of those 2 lines. So we will have something very similar to this legend where we're gonna say 2023 versus 2022 in order to explain those 2 lines, and then we're gonna explain those 2 circles. So in order to create the legends, what we're gonna do, we're gonna go to the legend of subcategory and let's go and duplicate it and let's give it a name. You're gonna be the legend of KPI. Let's just move the dashboard to the end in order to have all the sheets on the left side, and let's go to the legend of KPI and start formatting it. So now since we have different KPIs, not only the sales, I'm gonna go and remove the sales words in our text. So let's go to the text, to the 3 points, and then let's go and remove the sales, and let's have only the years. And then let's go and add our circle, and we're gonna say highest month, and another circle for the lowest month. Now, as usual, we're gonna go and start formatting those informations. It's gonna be Tableau medium and 9, so everything is fine. Let's go and change the color of those circles. So the highest is gonna be the blue, and the low is gonna be the orange. So let's go and hit OK and check the results. Looks nice, right? But I think here I have an extra space. So let's go to the text again and let's have only 1 space. All right, let's go and hit OK. And now let's go and use it inside our dashboards. So what we're gonna do, we're gonna go to the dashboard over here. Let's grab the KPI, the legend KPI, and let's drop it just below the title. So we're gonna have it between 2 horizontal containers. So let's drop it first, and the next step we're gonna go and remove the title. So let's go and hide it. So now it's really small between those 2 containers. What I'm gonna do in order to select it, let's go to the item hierarchy, and now we can check and see we have the container for the title, the container for the KPIs, and in the middle we have our charts. All right, so now maybe let's go and make the title just a little bit smaller, like this, and let's go to the legend KPI and like drag it a little bit below. All right, so now it looks fine, and we have an explanation for the 3 KPIs. All right, so with that we have everything ready inside our main container. What is missing, of course, is the hidden container where we have the filters, but I will leave that until the end. So now what we're gonna do, we're gonna go to the main container. Let's select it and remove the border and as well the background. So let's have none. All right, so now the final touch, the last step of formatting these dashboards, we're gonna go and add spaces in this dashboard between the charts. adding spaces between the charts gonna have a huge effect on the user experience for your dashboards. And as you can see, those two charts are really near to each other, like they are not able to breathe, right? So adding space between those two charts will not only add a balance between the items, but also it's gonna make it easier to read for the users. So now let's go and start adding those stuff. The first thing that we're gonna do is that we're gonna change the background color of the whole dashboard. So in order to do that, let's go to the main menu over here to the dashboard, and then let's go to the format option, and here the default gonna be white. Let's go and move it to the lightest gray. So let's select that. So now with that, we are separating the charts from the background, and we can see immediately the spacing between the charts. So now if you look to the 3 KPIs, you can see we have a minimum space between them, but between those two charts, there is no space at all. So now let's go and fix the spacing from top to bottom. First, I would like to have the background color of this legend to be a gray. So in order to do that, let's go to the sheet. So I'm just gonna switch to the sheet, and then let's go to the format. But if you don't have it open, just right click on that white space, go to format, and let's go to shading. So now we can go and color the background of the worksheet. So let's go and say none. All right, so now let's go back to our dashboard, and as you can see, for the legend over here, we don't have a coloring. We need a background color of white only for the charts. All right, so now let's start working on those 3 KPIs in order to increase the spaces between them. So in order to do that, let's go and select the first one. Let's close the format, and let's stay at the layout. So now here, if you go to those two options, we have the outer padding and the inner padding. The outer is the space between the objects, and the inner is the space inside the chart itself. So now what do we need? We need to increase the spacing between those 3 KPIs, and as well the spacing between the KPI and the charts. Alright, so now let's go and start with the outer padding. Let's click on it. And now here, as you are increasing the numbers, as you can see, the padding, the spaces between this chart and the neighbor charts gonna be increased. And as you can see, it's gonna increase for top, right, bottom, left. So as you can see, everything is connected together. If you change something here, it's gonna change for all values, and that's because all sides should be equal. And here, it's very important to understand that you have to make a decision about the spacing between your charts, and you have to commit to your decision for the whole dashboard. This is really important, otherwise the dashboard gonna be ugly. So now we're gonna go with the value 20 for all the charts inside these dashboards. So now let me show you how we can do that. Let's go and make everything to 10. And now what we are doing, this chart is taking a 10 on the left, right, top, bottom, and our goal is to have a 20. So if this chart on the right side is taking a 10 and the neighbor KPI is taking from the left side as well 10, then we will have a 20. So that means in order to have a 20 between all our charts, each one of them should has a 10. But now I care only for the spaces between the charts and not the legend over here. So what we're gonna do, we're gonna go to the outer padding over here, and then let's remove all sides are equal, and from the top I really don't care, so let's make it as a 0. So now our chart is not taking any spaces to the top, we are taking only space to the right, bottom, and left. So now let's go and do exactly the same for each KPI. So let's go to the profits, go to the padding, we have to have it here as a 10. And now let's go and disable all sides equals, and we don't need any spaces to the top. Alright, so let's move to the next one, the same stuff, make it 10, and let's remove the top. So now we can see clearly there is a space between all those 3 KPIs, and this space is equal to 20. So now let's go and add spaces to the 2 charts over here. So make sure to select the whole container, and now the same thing, we're gonna go to the padding over here. And now we're gonna make it a 10. This time we care about the top to be 10 in order to have a 20 between these charts and the KPI above. Alright, so that's all for these charts. Let's go to the next one and do the same. So make sure to select the whole container and let's move it to 10. Alright, perfect. Let's go and deselect. So as you can see, the whole look and feeling of our dashboard look more professional and easier to read. And this is exactly why we add spacing between our charts. Okay guys, now not only the spacing between the chart is important, but as well the inner spacing, the inner padding is important between the content and the border of the content. And as well adding spacing inside the container or the contents gonna make things look more better. So for example, let's go to this KPI over here. You can see the total of sales is very close to the border, right? So now what we're gonna do, we're gonna go to the inner padding, and now let's go and increase the size a little bit and see how things looks like. Let's make it maybe 7. So now as you can see, as I'm increasing those numbers, the content are getting pressed and move away from the border. So if you increase it, for example, like to 20, and as you can see now, we have a lot of spaces between the title and the border of the content. So now let's go and move it to 7, and we will go and do the same for all other KPIs. So let's go to the right one, and we're gonna make it 7, and to the third one, let's go and make it 7. So as you can see, moving the content away from the border a little bit, gonna make everything breathe better. Let's go and do the same for all other charts. So I'm gonna go over here to the whole container. Let's add a 7 as well over here, and add a 7. Alright, so that's all. With that, we are done formatting our dashboard. The next step is that we're gonna go and start working on the filters and the interactivity. And now let's check quickly what was the requirements. We have to allow the users to filter the data by the product informations like category and subcategory, and as well by the location informations like the region, states, and city. And we have another requirement about interactivity and filtering. It says we have to allow the users to use the chart and the visuals as a filter. Alright, so now let's go and add the requested filters. We didn't add any filters inside our worksheet, so let's go to any of those worksheets, for example the KPI sales, and let's start adding the filters. So the first one was about the product informations. So let's go and get the category, show filter. Then let's go to the location information. Let's add the country. Alright, so those are the filters that are requested from the users. The next step is that we're going to go and apply them for all worksheets. So since all those filters are relevant for all our charts. So let's go to the first one, right click on it and apply to worksheets. And then let's say all using this data source. So let's go and select that, and as you can see now we get a small icon indicate that all worksheets using this data source can have this filter, the category. Let's go and do the same for all our filters. So using data source, state as well, and the city. So now we can go and test that. If you go to any other sheets, we should see all those filters. So as you can see, all our worksheets has those 5 filters. Alright, so now the next step, we're gonna go back to our dashboard and start adding those filters. So let's go to the sales dashboard, and you know that for the filters, we have an extra container for that. It is currently hidden. So as you can see, the first container here, the vertical container, and it is hidden because we are using a button. So let's go and show it. In order to do that, we're gonna go to this small icon and then right click on it, and then let's say show. So once we do that, we will get our mini container for the filters. So now let's go and start building this filter container. So I'm just gonna move it to the right side over here, make it to the whole side, and then a little bit wider. Alright, so now as you can see, we have got a lot of information that we don't need. We got it automatically from the charts. We have our own legends. So let's go and start removing those stuff. We don't need anything. But I'm just gonna leave the parameter. So let's just leave the select here. And now we have to go and start adding the filters. So since our filters are everywhere in each chart, doesn't matter which one you can select. Let's go with the first one over here. Let's go to the arrow, and then here we have the option of filters. And let's make sure that we are selecting the filters that we need. So let's start with the category, and let's go add the second one. It's gonna be the subcategory. So it's over here. And then let's have the location informations. It's going to start with the region. And then the next one, let's go to filters. We're going to have the state. And the last one going to be the city. So filters. And with the city, we have it over here. So as you can see, as we are adding filters in our dashboards, it's going to be automatically added to this container. Alright, so now the next step is that we're going to go and start changing the structure of those filters. And we will have a drop-down menu using multiple values. So let's go to the category over here. Let's go to this arrow and make sure to select multiple values drop down. So we're gonna do it for all those filters, to the region as well, state, and the city. So this is how I usually go with the filters in order to have more space, but you have to discuss it with the users. Maybe some users gonna say, okay, one of those filters are really important and they want it as a list. So of course, if it has low cardinality, then it's no problem. Alright, so that's all the required filters for this dashboard. Let's go to the next step where we can start formatting, coloring, and as well cleaning up this container. Okay, so now the first step is that we're gonna go and change the color of the background. So select the container, let's go to the layout. And we don't need any borders, but we want to change the background color. So let's go and select our color, but this time we're going to go and make it really dark. So let's make it darker. Okay, like this. Let's go and hit OK. Alright, so now the next step is that we're going to go and start grouping up those filters into groups. So the first two, the category and subcategories, those are informations about the product, and the region, state, city, they are about the location. So let's go and give this information to the users. So what I'm going to do, let's go to the dashboard, grab a text, and let's just put it before the category. So the first one is going to be about the product. So let's write the following: product. And then after that, 2 minuses. Let's go and make everything bigger. So let's check the 11. Let's have it in the middle. And let's go and change the font to something like light. And as well, let's go to the coloring and pick our color. But let's make it a little bit lighter. Something like this maybe. Alright, let's go and hit OK. Alright, so now one more thing what we can do, we can add spaces between each character just in order to make it like a title. So let's add just spaces. Okay, so let's go with that. Let's hit OK. So with that, we got like a group name for the next two filters. Let's go and do the same for the location. So we're gonna go and grab a text, the region over here, and we're gonna do the same. So location. We will do exactly the same formats to the middle, and as well let's pick the Tableau light. And now let's go and add the spaces between the characters. Alright, and let's do the coloring. If you go to the color over here, you will get from the history the last used color. So with that, we get exactly the same coloring for the product. So that's all. Let's go and hit OK. Nice. So with that, we have grouped up our filters, but let's go and add more spacing between those two groups. So what we're going to do, we're going to go and grab a blank, and let's just do it before the location. All right. So now with this blank, you can decide on the size of the space between those two groups. So let's go with something like this. And let's have as well a blank between the year and the product. So let's grab a blank over here. And let's just put it here so that we have like an extra space between them. And you can control the height of those two blanks by going to the layout over here. If you select it, you can see the height. So as you can see, both of those are almost identical. So everything is fine. So now we're going to go and add a title on the top. It says those are filters. So what we're going to do, we're going to go and grab a text from the dashboard over here. Let's just put it at the top and let's call it filters. As well, you're gonna be a light. Let's make it bold, and let's make this title as 14. And we can go over here and add spaces between those letters, and we can make this one as a white. All right, let's make it as well to the middle. Let's go and hit OK. And as well, we can go and control the spacing by adding a blank on top of it. So let's go and add a blank at the start. So with that, we control the space between the border and this title. So that's it. I'm really happy how it looks like. Let's go to the next step where we're going to go and start positioning this container. But now in order to place it in the correct place, I need to understand the border of the main container. So let's go back to the layout and select the main container again. I'm just going to add a border to it in order to see it. So with that, we can see this is the border of our dashboards, and let's go and position this container exactly on the borders. Okay, so now how are we going to do that? Let's go to the positions over here and make the Y to 0. So let's change it to 0. And now with that, we start exactly on the top, but for the bottom and the right, we have to do it manually. So let's start moving stuff exactly on top of the borders. All right, perfect. So we have it exactly on the place where we need it. What I'm going to do, I'm just going to go and make it a little bit smaller. And now the next step, we're going to go and start adding spaces inside the container itself, just to make it look professional and not everything on the edges. So let's go and give it some spacing. So what we're gonna do, we're gonna click on the whole container again, and let's go and add some inner padding. So let's go over here, and I would say let's just move it and see how things looks like. Maybe let's go with the 10. So now as you can see, those boxes does not start immediately on the border, and it's going to be easier for the users to select. Alright, so now we are done cleaning, formatting our container for the filters. We can go and start testing, right? So let's go for the year and change this year to 2022. As you can see, all numbers did change, which is perfect. Let's move it back to 2023. Let's go and pick another category. So let's have only the furniture, and as you can see, the dashboard is reacting, which is really great. And now of course we can go and remove the all over here because it's not really needed. We have really low cardinality in this filter. So let's go over here, and then let's go to customize and remove the show all values. Okay, so now if you go again here, you will not find the all. For the low cardinality dimensions like this, we don't need it. For high cardinality dimensions, like for example the subcategory, here it really makes sense to select everything. So that's why I'm gonna go and leave it over here. Let's go to the next one, to the region. We have here only 4 values. Let's go and remove the all, and as well we can start testing. So as you can see, everything is working. All right, so that's all about the requirement of having filters for the users, for the product and the locations, and we are done. Let's go now and hide this container. Don't worry about the icon. We're going to change that in the last step of the dashboard, in the final touch. So let's go over here and hide it so that the whole container did disappear. Let's talk about the second requirement. So the requirement says to have interactive charts. That means if you click on somewhere on the charts, it's going to be used as a filter for the other charts. So for example, if I go and click over here in this subcategory, it should go and filter the other charts. So in order to do that, it's really easy. Just click on the charts and select this small icon over here as use as filter. So once you select that, it's going to be filled, and if you go and click around, you can see the other charts can be filtered. So we are now adding dynamic and interactivity to our dashboards. Let's go and do the same for the other charts. So let's fill it and use it as a filter. I think for the KPIs, it doesn't make sense to use it as a filter. So make sure to discuss that with the users, whether they want their KPIs to be used as a filter. So for now, I'm just going to leave it as it is, and we can go and use those two charts in order to filter the data. So for example, if I go over here and select all those data points, you can see the data is filtered in the other charts. All right, so as you can see, it's really easy, and with that we have fulfilled this requirement, and with that we have added the filters and the interactivity aspects to our dashboard. Alright, so now finally we are at the last step of the dashboards, where we're gonna have the final touch by adding, for example, icons. And if you downloaded the project, and I hope you have downloaded from the description link, what you're gonna do, we're gonna go to the project over here, and you can see we have a folder inside the project called icons. So let's go inside, and with that we have around 5 icons that we can add to our dashboard. So let's go and add them. Okay, so now first we're gonna start with the icon of the filter. So click on that, and let's go to more options, and let's go and edit the button. And here in this window we can configure 2 options: when the item is shown and when the item is hidden. So now let's start with the first one, as the item is hidden. That means the whole container is hidden as the current situation. So let's go and choose an image for that, or an icon. Let's go to our project, and we will use this icon in order to indicate for the users. If you click here, you will find the filters. So let's go and select that. All right, so that's all for now. Now we're going to go to the opposite scenario, where we can see the container and we want to minimize it or close it. So here we have another icon. Let's go and choose the image of closing. This one. Okay, so that's all for now. Let's go and hit OK, and with that you can see now our icons. Let's just make it bigger in order to see it, and let's go in the presentation modus in order to understand how this gonna work. So let's go and present, and as you can see we have a big icon here. If we click on that, our container gonna appear, and then it's gonna switch immediately to the second icon, and if you click in the second icon, the container gonna disappear. Alright, so this is how it works. Let's hit escape and go back to our developer modus. So now let's go back to the button and edit it. And here we have to give the users a tooltip if they mouse hover. So let's go and say something like show dashboard filters if the container is hidden, in order to show the container. And let's switch to the other one, and let's say close dashboard filters. So let's go and hit OK, and if you mouse over on the filter, you will see this small tooltip. Alright, so that's all for now. Let's just move it to the right side, and we will configure all those stuff later once we add the logo to our dashboard. So now I would like to place the logo just before the title. In order to do that, let's go to the dashboard, and here we have an object called image. So drag and drop it just before the title over here inside the container. And now we have to go and choose the image. So our logo gonna be this one. Let's go and hit OK, and then let's go and choose those 2 options to fit just in the center. So that's it. Let's go and hit OK, and with that, as you can see, we have a nice logo at the start, but let's go and just make it bigger. So I'm just gonna go and select the whole container, just make more space for it, and maybe just move the title a little bit to the left side, squeeze it. Alright, so it looks nice, right? Alright, so now before we continue, let's go and check the layout, whether everything is fine. Just gonna make it a little bit bigger over here. So here we have the title container, and inside it we have the logo, the title, and then we have the buttons over here. So far everything looks good, but one thing that I have noticed that the legend here is a little bit shifted to the left. It does not align with the KPIs. So I'm going to show you now a trick in order to test that. If you go and change it to floating, and let's get a blank. And let's go and format this blank to have, for example, a border, and then let's have any background color for that. Alright, so now we're going to go and use this in order to test that everything aligned. So what we're going to do, we're going to just move it over here, exactly on the border, and as you can see, the 2 is outside. So that means we have to go and adjust the padding of our legend. So select that, and now let's go to the outer padding, and let's remove all sides are equal and start working on the left one. So let's go and start increasing. So with that, the 2 is inside and everything should be fine. So if I go and deselect, remove my test from here, and as you can see, everything looks really clean. Alright, so this is how I usually test stuff if I'm not sure on the visual. So let's go and remove it. Now great, we have the logo, we have the icon for the filters. So we would like to have the sales dashboard and the customer dashboard as an icons. We don't want them as buttons. So in order to change that, what we're gonna do, we're gonna go to the buttons over here. Let's go and edit it. And now instead of having a text, we're gonna have an image. So let's go and choose another image, and this can be for the sales. So let's select that, and we have the tooltip from before. Let's go to the customers and do the same. And we have for the customers another icon. It is this one. Let's go and hit OK. And we have a tooltip, so everything is fine. Let's go and hit OK. So now as you can see, we have now 3 icons, one for the sales, one for the customers, and one for the filters. Alright, so now what we're gonna do, we're gonna go and add all those icons in one container. Alright, so now currently we have one floating icon and 2 others inside container. So let's go and change this one from floating to tilde. In order to do that, let's go to the options, and let's remove floating from here. So now it is somewhere inside our dashboards. Let's go and place it next to the others. So make sure inside the container. Alright, so with that we have everything in one container. The next step of that, I'm gonna go and change this container to a floating container because I wanted to place it freely where I want. So in order to do that, make sure to select this small container over here. Let's go to more options and change it to floating. And next I'm just gonna move it exactly to the border to make sure that we have it in the correct place. So now we have the border exactly on the filter. I think it looks really nice. Let's move it a little bit up. Okay. Alright, so now everything looks really perfect. The icon over here is grayed out because we haven't selected what can happen if the users click on this icon because we still don't have the customer dashboard. Don't worry about it, we're gonna have it later. Alright, so now the last touch, we're gonna go and remove the whole border of this container. So let's go and remove it. Alright, so now we are almost there. What I'm gonna do now, I'm gonna go and test the container inside the filter to see everything is working. So let's go and show the filter. And now let's go and adjust few stuff about this container. So double click on the container, make sure everything is inside. And now in order to control the spacing, we have added before a blank at the start, remember? So if you go to the blank inside this container, the first one, we can go and push the content down, maybe something like this. And with that, this container is as well clean. Let's go and hide it. And I think we are done. So let's go and test the final result by going to the presentation modus. Let's go and test this container again. And I think everything is placed perfectly and really we have a nice dashboard. Alright, so guys, we are done with the sales dashboard from the requirement until a very professional dashboard. So now next we're gonna go and do all those stuff again for the customer dashboard. So now here is your task to pause the video or come back later to the course in order to work on the customer dashboard. And once you are done, we can continue in the course in order to show you how I did prepare it. So now go through all the steps, starting by analyzing the requirements and ending up by having a customer dashboard. So now since we have those 2 dashboards in one project, I'm gonna say let's go and copy a lot of stuff from the sales dashboard and reuse it in the customer dashboard. So see you soon. Alright, so now I hope you are done building the customer dashboard. Now I'm going to show you my version, how I did implement it. So now let's have a quick overview on the requirements. Let's start with the key requirements. We have here the same stuff. It says that we have to show KPIs, where the KPI should display the total number of customers, sales per customers, and as well the total number of orders for the current year and the previous year. And the next requirement is about the trend. We have to present the data on a monthly basis, where we have to compare the current and previous years, and as well we have to identify or to highlight the highest and lowest values. So those 2 requirements are exactly like the sales requirements, but with different measures. So for the chart type here, we're gonna go exactly like the sales dashboards, where we're gonna have bands and as well spark lines with small circles. Alright, moving on to the third requirement, we have the customer distribution by number of orders. So here we have to present the distribution of customers based on the number of orders. So here we are talking about data distribution, and for that we have a perfect chart. We have the histogram. Okay, so now for the last requirement, we have to show the top 10 customers by profit. So here we have to show the top 10 customers with the highest profit, and as well they need a lot of informations like the rank, number of orders, current sales, current profit, and the last order date. So here in this requirement, we have to present a lot of details about the 10 customers, and for this I have decided to go with a symbol table where we're gonna have rows and columns. Alright, so this is about analyzing the requirements and deciding on the chart type. For the next step, we're going to talk about the mockup and the coloring. We're going to use exactly the same stuff like in the sales dashboard. And that's because the two dashboards are in the same project and it makes no sense to create each time for a new dashboard, a new mockup. So here we have to follow one mockup for all our dashboards in order to have the same look and feeling of our dashboards inside this project. So as you can see, things goes easier for the next dashboards. Now we can go and start implementing the charts in Tableau. Alright, so now for the first charts, we have the 3 KPIs, customers, sales per customers, and orders. They are the usual stuff like before. It's just copy and paste and switching the measures. And of course, if you are interested in how I implement it, I'm gonna leave the file as well in the project, or you can go to my public profile and download it from there. Maybe one interesting thing to show you how did I calculate the sales per customers. So let's go over here. And since now we have a lot of fields, we can go and search for customer in order to check the calculated fields. So first we have to decide which customers did order for the current year and which one did order for the previous year. So it's really simple. If we go over here to the current year customers and let's go and edit, you can see over here we have the same condition. If the year is equal to selected year from the parameter, then show the customer ID, otherwise it's null. With the previous year, we're gonna have exactly the same but subtracting 1 year. So this is the first step. Then the next step, we're gonna go and calculate the current year sales per customer. So we have it over here. Let's go and check inside it. So for that, we have the following calculation. We're going to divide the current year for the sales by the count of the distance value of the customers. And with that, you're going to get the average sales per customer. So we will do the same stuff as well for the previous year. And the rest is going to be as usual. So finding the differences and finding the min-max values. So that's it for the sales per customers. Now let's go and start implementing the first chart using the histogram in order to show the data distributions for the customers. So let's go and create a new sheet and we're gonna call it customer distribution. Alright, so now since we are talking about two measures, the count of customers and the count of orders, we have to go and use the LOD expressions in order to generate the pins. And I explained that in details in the LOD expressions using the fixed. So make sure to check that in order to understand the LOD expression that we're going to use now. And for that, we're going to go and convert the number of orders into pins using calculated field. So in order to do that, let's go and create, let me just remove the search. Create a new calculated field. So here we want to find for each customers how many orders they placed. And of course we are talking for the current year. So for that we're going to go and use the function fixed from the LOD expressions. And then we have to define the dimension. It's going to be the current year for the customers. So here we have all the customers that did order in the current year. Then after that we have to do the aggregation and it's going to be the number of orders. So we're going to go and count distinct as well the current year for the orders. The current year for the orders is like the customers, all the orders that are placed in this year. Alright, so that's all. Let's go and close the fixed over here. Alright, so again what we are doing over here, for each customers we are going to find the number of orders that they are placed for the current year. Alright, so now let's go and hit OK. And now we have it over here as continuous measure. Let's go and change it to a dimension. So right click on it and make it a dimension because pins in the histograms are usually discrete values. So now what we're going to do, we're going to go and test the values. Let's drag and drop it to the view. Okay, so with that we got our pen for the histogram, but I would like to go and test those data. So in order to do that, let's go and create a new sheet. Let's call it test histogram. So what we're going to do, we're going to go and check our customers. So let's pick the customer name. And now as well, let's go and grab the ordered ID over here. Let's show all the values. And as well, we need the date. So let's go and pick the order date. It is over here in order to see the year. And then what we're going to do, we're going to go and check our new calculated field. Let's drop it over here. And then let's go and switch it to a measure and sum. All right, I will go and drop it on the labels. All right, so now let's go and check one of those customers. Let's focus on Adam Hart. Right click on it and let's say keep only. So now we can go and check all orders of Adam. And as you can see, we have a lot of orders in the history and none of them going to be counted inside our calculated field because we are focusing only on the current year. So as you can see, we start counting from 2023 and in 2023, we have 5 orders. So 1, 2, 3, 4, 5. So as you can see, the measure is returning a correct value. We can go and test the other years. For example, let's go and show the parameter and let's go and switch it to 2022. So with that, as you can see in the 2022, we have only 3 orders, Let's go and switch it to 2021, and we have here only one order. So that means our calculated field is working as intended, and we can use it now for the histogram. So this is what I usually do once I create a new calculated field, especially if it is LOD. I go and test it. So I create a simple table in order to see the data and focus, for example, on this one customer, instead of testing directly in the histogram, because it's really hard in the visuals to test the data. Alright, so now let's go back to our customer distribution and let's get our bars. In order to do that, we're gonna go over here to the rows, let's say count distinct, and now we're gonna go and count the customers for the current year. So the current year customers, let's go. And now we have to go and change the visual to bars, since histograms are bars, and with that we got our histogram. So that's it. Now next we're gonna go and start formatting our histogram. So the first thing, as usual, we're gonna go and remove the lines. So let's go and format, let's go to lines, let's go to rows and remove the grid. Alright, so that's all for the lines. Next, we're going to go over here and remove the headers. And let's make those pins and make it more readable. So let's go and format it. Maybe I'm going to make it bold and change the color. Alright, so now we have the name of the dimension over here. We can go and hide it. Okay, so now let's go and start with the coloring. Let's hold Control and drag the customer to the colors. And of course, we're going to go and use our coloring. So let's go and edit it. And let's pick the blue one. Alright, so that's it. Let's hit OK. Okay, next we can go and add some borders to those bars. So let's go to the colors, to the borders, and make it something like this. Alright, so now the next time I'm going to go and add some labels. So let's get the customers to the labels. And I think with that, we are done with the histogram. We can go and test it by adding the parameter. Let's select another year like 2023. And as you can see, everything is reacting. And that's it for this requirement. Now we are showing for the users the distribution of customers by the number of orders. Let's go now for the next requirement, where we're going to show the top 10 customers by the profit. Alright, so now let's go and create a new worksheet. Let's call it top customers. So now we need our customers to the rows, and now we're going to show only the top 10 customers by the profit for the current year. So let's go and get our measure. It is the current year for the profit. Let's drop it on the text over here. And now next we're going to go and make the filter in order to show only the top 10 customers. So hold Control, drag and drop the customer name to the filters. And now here we're going to go to the tab of top, and then let's switch it to by field. So we have top 10 by the profits, and the aggregation going to be the sum. So this is exactly what do we need. Let's go and hit OK. And with that, we're going to get a very simple list of the top 10 customers by the profit. Let's go and change the format in order to see the whole number. So let's go and format it, where I'm going to go and remove the unit. So remove decimals, and let's have the $sign at the start. Alright, so now we can see the whole number. Let's go and sort the list by the profit. So in order to do that, go to the customer name, and then let's go to sort. And we're gonna go to a field, and in order to have a ranking, we're gonna switch it to sort order by descending, and make sure that we have the field name current year of profit. Alright, so that's all. Let's close it, and as you can see, the first customer on top, it's gonna be the top customer. And now the next step is that we're gonna go and add the rank to this list. So in order to do that, we're gonna use the function index. So let's go to the rows over here and just write index. And that's it. And then let's go and switch it to discrete and just put it at the front. And with that, we have a ranking from 1 to 10. Alright, so now we're going to go and add additional informations for each customers, like the sales for the current year. So let's go to our data pane and let's grab the current year for sales, drag and drop it on top of those numbers. So with that, we can see as well the sales for the current year. Let's just make it a little bit bigger. And now the next information that we're going to go and add is the number of orders for the current year that is placed from the customers. So in order to do that, let's go to the measure value over here and double click on the empty space and write down count distinct in order to count the orders. So we're going to go and type current year of the orders. Alright, so let's hit OK. And now we're gonna see the number of orders that each customers did place in the current year. Alright, so now the next information that we're gonna add is the last order date did the customer place. And now we need the last order date. In order to do that, right click on it and let's go to the measures and get the maximum. So with that, we can see now when was it the last time did our top customer order from our business. Alright, so with that, we got all the informations that we need inside our chart. The next step is that we're gonna go and start formatting it. So first we're gonna start with the lines and the grids as usual. So right click on it and go to format. So now I would like to get rid of this line in the middle between the measures and the dimensions. So let's go to the grid and let's go as well to the column divider and remove it. So with that, we don't have the line in between. And now the next step is that we're going to go and get rid of the gray background color. So let's go to the shading, and then here we're going to go to the row banding and reduce the size to the minimum. So with that, as you can see, the background color did disappear. Alright, so that's all for the lines and the grid. Let's go and start formatting the fonts and the colors of our fonts. So first I would like to format the index over here. So let's go to it, format. So let's go and make sure that we are selecting the correct field. So yeah, we are selecting it. Let's go to pan. And now let's go to the numbers over here, and I would like to add a prefix. So let's remove the decimals by the number custom and add the prefix of hash in order to have like a ranking. So that's it. And what else we can add to this ranking is that we can go and add the background color for it. So go to the shading over here and make it very light gray. Alright, so that's all for the ranking. Let's go to the next one and start changing the font color. So format it, and let's go to the fonts. So we can leave it as a Tableau book, and we can go and change the color to something like black. So that's it. Let's go to the next one, format. And we're gonna go over here, make it black. Alright, so now moving on to the measures, let's go and remove the unit from the sales. So let's go to the sales over here, format, and then we're gonna go and format it as usual to the number custom, remove the decimal and add a $sign. Alright, and for the number of orders, we're gonna leave it as it is. Alright, so that's it. Let's just keep it very simple. And with that, we have a really nice detailed table to show the top 10 customers with additional informations. Alright, so with that, we are done building all the charts. The next step, we're gonna go and start building the dashboard. Okay, so now in order to create the customer dashboard, we will not create everything from the scratch. We're gonna go and duplicate the sales dashboard in order to have the structure. So let's go to the sales dashboards, right click on it and duplicate. So with us, we got two identical dashboards. Let's go to the second one and start formatting it. First, we're going to start with the naming. So it's going to be the customer dashboard. And now let's start from top to bottom. We're going to start with the title. So let's go over here, change it from sales dashboard to customer dashboards. So now as you can see, creating the second dashboard can be very easy once you have a really solid structure. Alright, so now next what we have the three charts. We're going to go and replace them all with the new ones. So the first one is going to be the KPI customer. Let's just drop it here at the start. And of course, Tableau is going to go and start adding stuff to our new container. Don't worry about it, we're going to go and delete it later. So let's go and get the next KPI, sales per customers, and the orders. Okay, alright, and now let's go and hide this container. So right click on the icon and let's go and hide it. Alright, so now we can go and drop those old KPIs from this dashboard. So let's just remove them. And with that, we got our three KPIs. Let's keep moving and add our charts. It's going to be the histogram. So let's drag and drop it below the legend over here. And we can go and remove the old stuff. So the old chart, and as well, we don't need the legends. So let's go and drop the whole container for both of the legends. And let's go and change the title to customer distribution by number of orders. Okay, so let's hit OK and let's remove the title from the chart. Okay, so as you can see, this container keep popping up because we have a new legends and new stuff. So let's go and hide it again. And let's work on the right chart. It's gonna be the detail list for the top customers. So let's drop it over here and we're gonna go and remove the old one. And now we're going to move on to check that everything fits the entire view. So let's go check one by one, entire view, this one as well. Everything looks fine. Let's check the last table. Okay, so it's standard. Let's go and switch it to entire view to use the whole space. Alright, so now we put everything together in one dashboard. The next step is that we're going to go and start formatting this dashboard. And it will not be that bad because we have almost everything. So let's start with the first chart. Let's make everything with a white background. So let's go to layout and change it to white as well for the next KPI, just to make sure that we have done for everyone. Alright, so with that, we got like a card for the whole KPI. The next step, I would say, let's go immediately and start working with the spacing between those charts. So let's click on the first one. If you remember on the sales dashboards, we have agreed to have a 20 between each charts. So let's go to the outer padding and make everything as a 10, but only on the top. We don't need this extra space. So let's disable all sides equal and make it 0, only for the top. And as well, we said the inner padding gonna be always 7. So let's have it like this and do it for the others. So outer is 10, on top is 0, and the inner padding gonna be 7. And as well for the last one. So you are 10, remove it for the top, and the inner gonna be as well a 7. So let's do it like this. Alright, so with that, we are done formatting the 3 KPIs. Let's move on to the charts. So now let's go and select the whole container. And as you can see, we have everything done as before. So the outer padding is 10 and the inner padding is 7. Great, let's go and check the right one. I think we're gonna have it as well correct. So as you can see, things get really fast as you are building the second dashboard using a solid structure. Alright, so now we're gonna do one more thing about the top 10 customers by profit. As you can see, those header informations or the field name is not really nice. So now we're gonna go and remove those informations and we're gonna build our own custom field names. So let me show you how we're gonna do that. Let's go to dashboard and let's grab a horizontal container on top of our table. And here we're gonna go and put inside this container the field names. So let's just make it a little bit smaller and let's start adding texts. So this is the first text. So the first information gonna be the rank. So let's have a rank. Let's change the font to a medium and let's change the size to 10 and make it a little bit lighter for the colors. Alright, so let's go with this. Let's hit OK. And let's go and add another one for the next field. So make sure to be on the right side. Customers. And we're going to do the same stuff. You're going to be medium, a 10, and this color. We can go and copy it for the next one. So let's go and hit OK. And now let's go and keep adding our fields. So the next one going to be the last order date. So let's paste the old one and we're going to call it last order. So that's it. Let's hit OK. And then we have the current profit. So let's grab a text. And instead of the current profit, I'm going to go and add the parameter and then the word profit. Let's go and make sure that everything has the same format. So you're going to be Tableau medium, 10, and the same coloring. Let's copy it for the next one. So we're going to add another text for the sales. Paste it. Let's have a sales. And the last one going to be the number of orders. So let's write it like this. Paste it. Remove the year. We don't need it here. So that, as you can see, we got our titles. What we're going to do, we're going to go and remove the titles from the original table. So let's hide the field labels and as well let's hide the header. Alright, so next we're going to start working on the alignment between the titles and the detail list. So we're going to start moving stuff around. First I'm going to go and make it a little bit bigger and then we're going to start moving those boxes on top of their informations until everything matches. So the last order a little bit to the right side, maybe make this field a little bit smaller and then let's go and push the sales a little bit to the right side and as well the profits. And now we're going to go and push this as well a little bit to the right side. As you can see, we don't have any more spaces for the order. Let's go and just call it orders. Alright, and we're going to go and move it again a little bit to the top. Okay, so I'm happy with that. Everything is perfect. And now we have formatted all the charts that we have inside the customer dashboard. Next, we're going to go and start cleaning up the filter information. So let's go and show the filter what is happening here. Okay, so now what we're going to do, we're going to go and remove all additional informations that Tableau did add to our new container. We don't need all those informations. So let's go and remove them one by one, and with that we got exactly like before the same container. And of course you can go and start testing your dashboard again. So we can go and switch it, for example, to 2022, and as you can see everything did change. Even we have a new top 10 customers. We can go and add, for example, different subcategories and everything is reacting. So everything is perfect. Let's go and put everything back to 2023, and with that we have fixed our filter. Let's go and close it. So let's hide it. Alright, so now the next step is that we're going to go and add interactivity in those charts. So make sure to select the histogram and use it as a filter. And with that, if the users go anywhere and start selecting stuff, for example, those two, and with that, as you can see, the dashboard is reacting. Let's deselect. Alright, so now let's do the same stuff for our top list. Let's go and make it as a filter, and now we can go and select our top customer, and we're gonna have a quick analysis only for this customer, which is really nice. So let's go and deselect that, and with that we are done with the interactivity inside our dashboard. Now moving on to the last step, where we're gonna work with the icons in order to make navigating our two dashboards very easy. Okay, so now let's go and fix this icon over here. So double click on it, and now finally we can see it's gonna navigate to customer dashboard. And now since we are at the customer dashboard, we're gonna show an icon that is like an active icon. In order to do that, let's go and choose the icon. So as you can see, this one gonna be the active icon if the customer select the customer dashboard. So let's go and select that. So now everything looks good. Let's go and hit OK. And with that, you can see we have a new icon that indicates we are now at the customer dashboard. Alright, so now next we're gonna go and fix the sales dashboards icons over here. So let's go inside it and navigate to the customer dashboard. And let's choose the one that is not active. So we're gonna go and select this icon. Alright, so that's all. Okay, so now let's go to the sales dashboards over here and change it to an active icon. So we're gonna choose this one over here, sales dashboards active. So select that and let's have an OK. Alright, so that's it. With that, we have fixed the icons. So the sales dashboard is going to be activated. If you go to the customer dashboard, it's going to be exactly the way around. Alright guys, so with that, we are done with the second dashboard inside our project. Let's go and test everything. So let's go in the presentation modus over here and let's check the data. Alright, so now we are at the customer dashboard. Let's go and click on this container over here. So as you can see, everything is working. Nice. So now let's go and switch back to the sales dashboard. So let's click on this icon. And now as you can see, we are back to the sales dashboard. So with that, the user should not go to the tabs and switch between those two dashboards. The users can just go and click on those icons in order to switch between those two dashboards. And with that, I'm really happy to announce our project is completed and we have fulfilled all the requirements. I will leave this project inside Tableau Public, or you can get it from the download link. Alright, so with that, we have completed our Tableau project and we walked through all the phases that I usually follow in order to implement any Tableau projects from the scratch, from the requirements until the delivery of the dashboards. And here again, my recommendation is that to not rush the projects where you can go immediately start building charts and dashboards without having a clear or organized plan. So do it step by step in order to deliver clean work. Hi, I'm very proud of you that you made it until the end. I hope you enjoyed the journey, and I know it wasn't easy going through all those complex tutorials, but you made it until the end. And now I can say that you have learned everything that you need to start doing amazing projects in Tableau. And as well, you have learned everything that I know about Tableau and how I usually implement real-life projects in Tableau. So now I'm gonna ask you for one more thing. If you found this video helpful and it helped you to start working with Tableau, I really appreciate it if you like it and share the content with the others. And of course, if you have any questions or suggestions for the next topic that you want me to cover in the future, or you want to give me a feedback, make sure to use the comment below. Well, nothing left to say. Thank you so much for watching this course, and I will see you in the next course. Bye.